There are two terms you need to know before starting database management system. First one is data and second one is information. So let's see what data means. So data refers to a collection of raw facts or figures that can be processed to derive meaning or knowledge. In easier terms, we can say any fact that can be stored is a data. So let's see from an example. Consider an example of orange. So what does orange means here? Orange can either be a fruit or can be a color as well. So we don't know what does orange means here. Maybe it can be a fruit, maybe it can be a color. So now comes information in the picture. So what is information? Processed data is called as information. So consider I am writing here as fruit. So now we are clear that we are referring orange, which is a fruit here. Consider I am writing it as orange and I am giving it the name as color. So now we are clear that here the orange we are referring to is the orange color. So basically what information does now, it gives a meaning to the unprocessed data. So data basically is a collection of raw facts or figures. You can also take an example. Consider there is a value called as 12. So now here, are you getting anything? What is 12? Maybe it could be an age. Maybe it could be a roll number. Maybe it could be a pocket money. So sorry, it couldn't be, but still I'm just taking an example. So here 12 can mean anything, like it is just a raw fact which is present here. Consider I'm giving it as 12 is the age. Now it is giving some process thing na ki okay, age 12. So my data is my brain is interpreting is ki okay, 12 might be an age of a person. So this is like what happens. So basically there is a data. We provide some additional information to it, like we provide some additional things to it and it gives me an information after processing it. So basically I have a data 12, I give it like age. Now my brain will process ki 12 and age. Okay, 12 could be an age of a person, so it gives me an information. So basically this is all about data and information. Let's see what's next. Okay, so database is the next thing we are gonna see. So what is database? Database is basically a collection of interrelated data. What does this interrelated data means? So there are also two pointers, like it can be stored in the form of table. It can be of any size. Now let's see, there are two examples of databases which are present here. So one is multimedia database and second one is college database. Consider that I am having a table which is having all information about an image. Okay, the pixels, the height and everything. I'm having another table which is having all information about a video, like pixels, length, everything like that. So kind of they are interrelated to a thing which is called as multimedia. So multimedia consists of images, videos, graphics and much more thing. So basically image and video kind of have a relation and these both interrelated data forms a multimedia database. Now in this example, there is a staff. There is a student. Consider there is a table 1 about the staff details. There is a table 2 about the student details. So kind of staff and student have a relation that they could be a part of a school database or a college database. So they are kind of having a relation. So they can be a part of college database and they are having a relation. That is why they are called as college database or database, like collection of a interrelated data. Now let's see from an example. So here you can see the example in. Consider this is an A1, this is a A2. So we have given the name to the table. First one is having an ID, name and subject. Second table is having ID, name and place for the same person, Rahul, Raj and Ritti. So here I have given the details about Rahul, like the ID is 1, the subject is physical education, ID is 2, the subject is economics, ID is 3, the subject is IT. Here I have given the information like ID is 1, the place is Delhi, ID is 2, name is Raj and the place is Kolkata, ID is 3, name is Riti and the place is Mumbai. So whenever I combine A1 and A2 together, they gave me a table A3 which is kind of having a relation, like it here if I combine A1 and A2, I can get a relation like the ID of Rahul is 1, The name is Rahul. The subject is physical education, and the place he lives in is Delhi. So basically there is a collection of interrelated data. So this is why database is called as a collection of interrelated data. Now let's see that why we need database. There was already existing file system. So what was the need of database? So let's see what is file system. So basically an operating system approach for organizing and storing data on storage units like hard drive is called as file system. So basically it is an operating system approach in which we store the data on storage units like hard drive. So what happens is, consider I am having a file called as a.txt and I have written some data like ID, 1, name, Riti. I've written some data in it. Now I want to save it. So what it will do is, it will go to the file system and the file system will call the hard drive to save that particular data inside it. a.txt. So basically you can say that a hard drive or a file system basically acts as an interface between the user and the data. So basically it acts as an interface. Now you would be having a doubt ki, okay, using this file system we were storing the data, we can also update the data, we can also delete the data. Then what was the need of databases? So basically there are some disadvantages of the file system. So the first disadvantage of file system is data redundancy. So what happens now ki, let's go to the 1980s time. So we used to have some registers. In first register, there might be some information about me, where I live, like the place I live, what is my age, and consider that there are two registers, okay? Registers. So there is two registers, register 1 and register 2. Register 1 is having knowledge about my name and my age. Register 2 is also having some data about my name and the place I live, okay? So basically there are two registers, register 1 and register 2. So register 1 is having data about my name and age. Register 2 is having data about my name and place. But again, there is a thing na ki, if it is having data about my name, information about my name and age, why not to incorporate place in the same register? Why to have multiple registers for a same person? So I'll be having one register with my age, one register with the place I live in, one register with the attendance, one register with some other data, one register about how much fees I pay. So there would be plenty of registers, right? So like kind of data is being redundant here, like it's being used in many formats at different places. So that is the major disadvantage of file system, that there is a data redundancy, that in many registers the same data is present about the same person. So that is the drawback of a file system. So this is something which we can achieve in a database management system or databases. Now the second one is poor memory utilization. Obviously, if I am maintaining hundreds of registers for a same information for a single person, there would be memory which would be filled. So there would be a poor memory utilization. Now the third thing is data inconsistency. So consider I am having two registers, register 1 and register 2. So register 1 is having my name and age. Register 2 is also having my name, which is Riti, age which is not 18, but I'm taking that 18, and please consider it as Bangalore, okay? So after 1 year, obviously I'll become 19 years old. So consider I'm making the change in this particular table register, that I'm 19 years old, my name is Riti and I'm living in BLR. But in this particular register, I forgot to make the change. So you can see that there is an inconsistency between data. The age is 18 here and here the age is 19. So there is data inconsistency which we can see here. So that is also a drawback of file system. Now coming to the fourth thing, that is data security. And data security is like the topmost priority. So we want our data to be secure enough. We want some security, some integrity in our data, some principles which should be in our data to restrict usage from like external people couldn't use my data, and which is not possible in file system. So data security is also something we achieve much more in databases rather than in file system. So that is the reason we introduced databases and we are not using file system. Now database management system, finally. So database management system is basically made of two words. First is database and second one is management system. So database, as we know, collection of interrelated data, and management system is basically a set of rules we use to access that data. Set of rules which we use to manage our data is basically called as management system. So the acronym database DBMS stand for Database Management System. User can access data, save data, retrieve it, update it, and manage it safely and effectively with the use of a software, program, or combination of programs. So again, the same thing, that in the database management system is basically a software which acts like we are having a database, right? In that database, consider we are having a database D1. So in that database, this is DBMS and this is an end user. So consider I am an end user. I want to make some insert into the database. Consider that there is a college database and on next day someone takes an admission. So I want to insert the data of that particular person who has taken the admission. So what I'll do, I'll use DBMS. Basically, DBMS is a software which is used to make some manipulation to the database like insert, update, delete, save, and much more things. Now, the presence of rules and regulations in the management system is crucial as they are necessary to uphold and maintain the databases effectively. So there should be some rules and regulations to manage the database so that we can uphold the database effectively and maintain our databases as well. So that is management system. Now, this is the application of database. So there are 3 applications which I have noted down, but there are much more applications of database. So the first application is database is being used in schools and colleges. The second application is database is used in banks. And the third application is database is used in airlines. So here we can see the application of database. Now the first application is school and colleges. So DBMS is used to create, maintain a student information system that stores student records including personal details, academic performance, attendance, and extracurricular activities. So consider I am a school student, okay? So whenever I take admission in my school, there would be an insert, like there would be already a school database which would be maintained. School DB which would already be maintained, which would be having data about the teachers, principal, staff, and much more things, students. Now consider I am a new student who takes an admission in my school. Okay? So whenever I take admission in the school, there would be some data related to me like my name, my age, which class I want to take admission, consider nursery. So there would be many data about me, that what I am, like what is my name, what is my age, which class I want to take admission, and much more thing. So basically that particular data is being stored in this particular database to keep the record of me. Okay, Riti is a girl which has recently taken admission to the school. Her name is this, her age is this, and she had taken admission in nursery class. So I'm just kidding, but I'm just giving you an example. Don't take it seriously. So these kind of data needs to be stored in the database. So here the application of database comes in. Because again, if you are maintaining many registers about people who are taking admission, people who are leaving the school, people who have been promoted from nursery to prep, like there would be numerous number of registers and it would be hard to manage every data. Then again, data inconsistency, data redundancy, there would be many things which would occur. So we use the database approach for this. Now again, in the bank, DBMS is used to maintain a centralized and secure database of customer information, including personal details, account numbers, contact information, and transaction history. So consider I am right now in bank. You come to me, you say that I want to open a new account in your bank. So right now I am having all the details about all the staffs who are working at the bank, all the people who have account with us, and much more things. So now a person comes in and he or she says that I want to open a new account in your bank. Again, he or she would be having some details like account number would be generated, then amount balance she or he needs to store in their account, and much more things. So that particular data I need to feed in the database. Now again, there is one more use case. Consider that today I deposited rupees 1000 to my bank account. Next day, I pull out 50 rupees from my bank account to buy some chips or something. So right now, what would be the current balance of my bank account would be 950. So there are some regular insertions, update, delete, and like some addition, subtraction as well in the database. So here also database comes into picture. So as you can see on my screen, there are many databases I have listed down, almost 11. But we don't need to know in depth about all the databases. There are some database we should be knowing a bit more depth, but we can get a slight idea on all the databases. So let's start. So on the very first, we are having relational database, that is among the most widely used databases. So in relational database, what happens? In that database, there is a collection of data items, which is kind of having some relation between them. So consider I am having a database or a table I am having. In this table, there are certain number of rows, certain number of columns, and these are having some relations in between them. So basically that is a relational database. Now coming to the second thing, that is NoSQL database. NoSQL means not SQL. So basically in NoSQL database, what happens na ki they don't follow any kind of format. So the data items are kind of stored in a key value pair. So what happens ki we have a key and we have a value, and our data is stored in kind of this key value pair. Consider an example, we have a key as place and the value being stored as Mysore. So there is no restriction or there is no relational way it follows to store the data. Like in relational database models, we basically use rows and columns to store the data, and it's like corresponding to this row, there should be this data, corresponding to this column, there should be this data. So we don't follow that much of strictness or that much of relational approach or a traditional relational approach to store our data. We store our data in the form of key value pair, which we basically do in a hash map. So now the third one is object-oriented database. As the name suggests, object-oriented. So basically whenever the data is stored in the form of object, it is called as object-oriented database. We will be looking more about this in the further slides. Now fourth one is in-memory database. So what happens in in-memory database? Now the database or the data is stored in memory, like it is stored in the primary memory, not in the hard disk or any SanDisk or SSD anywhere. So basically it is stored in memory. So that is why it is called as in-memory database. Now the fifth one is time series database. So in database, what happens now, ki consider we are having a series of events on a different time intervals. So that kind of events or that kind of time intervals are basically like a time value pair. It is stored in this time series database. Now sixth one is spatial database. So basically spatial is something like a kind of a, we can say a 2D thing or something which represents something. So basically in spatial database, what happens is ki we generally tend to store the geometric space in the database. Don't worry if you're not getting these terms, because it's just a basic intro of these databases. You don't need to know in much more depth about all these databases. Now the seventh one is multimedia database. So as the name suggests, it is a collection of databases which is having like collection of data which is having text, images, graphics, and much more things. Now eighth one is columnar database. So basically in this database, every data is stored in columns, not rows. Now ninth one is XML database. Again, as the name suggests, in this database, the data is stored in the form of XML. Now 10th one is new SQL database. So what new SQL database does na, ki there might be some gaps in relational databases. There might be some gaps in NoSQL database. So basically it becomes a bridge for all the gaps between SQL and NoSQL databases. 11th one is blockchain database. In this blockchain database, the data is stored in the form of blocks. So basically it is kind of a decentralized way in which data is stored. So data is basically stored in the kind of blocks. So there are 4 databases which we would be looking in depth, because relational database is kind of most used database. NoSQL database is also widely used, and object-oriented database and in-memory database, I guess according to the semester point of view, you should be knowing about it. Not very much in-depth knowledge, but you should be having some knowledge about it. So let's have a look on all these 4 databases. So basically the first one is relational database. So these databases structure data into organized tables that have predefined connections between them. So as I told na ki whenever like tables have some connections or have some relations among them, it is called as relational database. So consider there is a table 1 T1 and there is a table 2 T2. Consider that they have a kind of a relation between them. Relation, how you can say what kind of relation or something like that. So let's see. Consider there is a table which is having my name and my roll number. Consider the table T2 which is having my name and the place I live in. So this is also a data about me, and this table also contains a data about me. So they have a relation which is like the information about me is also present in this T1 and the information about me is also present in this T2. So this is kind of a collection of interrelated data. So this is like a connection between them. Now data manipulation and query performed using SQL. So basically in these kind of databases, the data manipulation like kind of insert, update, delete and every other operations are performed using SQL queries. Now well-known databases are MySQL, PostgreSQL, Oracle database and Microsoft SQL Server. So this is all about relational databases. Now coming to the second term, that is NoSQL databases. So NoSQL database are created to handle data that does not fit neatly into the strict setup of traditional relational databases. So what does this means? Again, like few minutes ago I told you what does NoSQL database mean. So basically in NoSQL database what happened now, we don't store in a form of rows and columns and we don't do any kind of queries ki theek hai, from this row we are getting this particular things, from this column we need this. So we don't do store data in that format. Basically data is stored in the form of key value pair, which I earlier explained. Consider there is a key called as place. So the value would be Mysore. So basically in a form of key value pair, the data is being stored. You can say in a form of hash map. And in relational database models, basically the data is stored in the form of rows and columns. They have some unique key which uniquely identifies the table. And there are more things in relational database model which is not followed here. So that is why it is called as NoSQL, that is not SQL. Like there are many things people say, but considering like it is a database where we don't use any SQL queries which don't follow any kind of relational databases. So the third one in this list is object-oriented database. So these databases hold objects utilized in object-oriented programming. So you might have heard about OOPS, that is object-oriented programming. What basically OOPS does, it stores everything as object. There are instances of object which is called as class. So basically in object-oriented database, the objects is stored as a form of data which are like instances of class, and the combination of objects and classes is called as object-oriented database. So they work well for the applications with intricate data designs like scientific simulations and multimedia software. So here they are mostly used. Now fourth one is in-memory database. So in this database, data is kept in the primary memory, that is RAM, rather than on a disk, leading to a quicker data retrieval. So basically in memory database, what we do now, we keep the data in the primary memory, not in the hard disk or not in the SSD. We keep the data in the primary memory, and whenever we keep the data in the primary memory, what it helps now, it helps to improvise the time, as we don't need to make some data retrieval from the SSD, rather than we can make the data retrieval from the primary memory itself. So they are employed in application that demand instant data processing and top-notch performance. Obviously it will give a top-notch performance because the time of consuming the data is very less. We are not consuming data from SSD or from hard disk. So need of database management system. So we got to know about database, databases के types, database management system, what is database management system, and much more things. Now we need to know that what was the basic need of database management system. So DBMS plays a vital role for business, institutions and organizations of all scales in effectively managing their data, ensuring data accuracy and security, and supporting essential decision making process. So basically what happens now, ki database management system is kind of having applications at every places, like in schools, like in colleges, like in banks and institution and much more places. It helps to easily manipulate the data, it helps to easily store the data, it helps to manage operations like inserting data, deleting data, doing some manipulation on the data like addition, subtraction and much more things. So it gives us the feasibility to do some manipulations on the data very easily. So that is the reason ki database management system is mostly used. Now the second reason is the security as well. It provides us a lot of security. There are a lot of user access control rules and some authentication rules as well, which would help us and help other people as well ki whenever we are accessing any data, there would be some kind of authorization present, so that that data would be accessible only from me, not from someone else. So it basically helps in data security, achieving security for our data and also the control of the data. So it serves as the core of contemporary information systems, facilitating efficient data management and serving as a basis for a wide range of applications and services. So as told earlier, it helps to manipulate the data, it helps to perform operations to data, it helps to secure our data, it provides a scalability also for our data, and there are much more things in which database management system could help us. So basically, along with the needs, we should also know the advantages of DBMS. So let's see. So basically there are various advantages of DBMS. I've just picked some of them which I thought were important, but there are various advantages of DBMS. So the very first advantage is data security. Who doesn't want their data to be secure? Consider you are in an institution or you are in a college. So no one wants ki your data should be insecure or your data should be visible to every person of the school, or anyone can access your mobile number, your email or the place you live in. So you want your data to be secured. So data security is mostly achieved in DBMS. DBMS implements security mechanism that regulate access to sensitive information, safeguarding it from the unauthorized access and potential data breaches. So the thing which I said earlier, consider there is a phone number of yours which is stored in the database. So there are some kind of security rules, there are some kind of security protocols which helps to provide a layer of protection for all the data, so that no one else from outside world could access your data, make some prank calls to you, or provide you any kind of advertisement. So basically that is the reason data security is something which is utmost important. Now second thing is data redundancy and inconsistency. I explained in the earlier videos as well, data redundancy basically means that same kind of data is kind of being used at different places. Rather we can have a centralized space where all the data for a particular person is present. And data inconsistency is ki consider there are many chunks of data which are present at different places or different registers. What if I correct a data in one of the register or update a data in one of the register and it's not updated in second or third register? There would be a data inconsistency. So DBMS removes all the data redundancy, minimizing storage needs and ensuring consistency throughout the maintenance of a unified version of data. So basically, as I told, in DBMS, we can have a centralized way in which we can store all our data at a central place, so that there won't be any data redundancy and inconsistency in data. So in database management system, now everything happens with a transaction. So in a transaction, what happens ki consider I am updating a data somewhere. So I need to update data at every places. So even if there is a system failure, transaction would help us to update the data. Either it will there are some many operations, read, write, read, and many operations which we would be seeing in the further videos. But with the help of transactions, we can achieve data consistency and remove the data inconsistency. So the third thing is data integrity. Now, DBMS guarantees data integrity by enforcing some rules or constraints that prohibit the entry of incorrect or inconsistent data into database. So basically, there are some rules in the database which prohibit the insertion of some inconsistent or some data which is not needed to be provided there. So consider there is a column called as age. So in this age, I can't feed the data like ABC, right? So this is not something which is taken care in the earlier systems which we are using, but in databases we can put a constraint that age could only be an integer. So it will not accept the values like ABC, it will only accept the values like 12. So basically we can put some rules, we can put some constraints so that any inconsistent data or any incorrect data is not entered into the database. Now the fourth advantage of database is database scalability. So DBMS can handle large data sets and scale to accommodate increasing amounts of data and as an organization growth. So consider that I am having an organization which is right now having 1 to 40 employees. So in my database, I am having data about all the 40 employees. What if I have a recruitment drive and I hire 1200 more people? So now there would be 1 to 40 employees and there would be some data. So I need to scale my database to that level that I can store all the information of 1240 people. So right now the total number of employees I am having is 1 to 40. Now I need to scale my database to that level that I can store all the information about 1 to 40 employees. So scalability is something which we can achieve in a much more easier way in databases. Fifth advantage is data abstraction. So DBMS offers data abstraction, allowing users and applications to interact with the database without needing to understand its underlying complexities. So there are many complexities, there are many hidden details which are present. So database management system makes sure that there is a data abstraction. So I know that an email is being sent to me from this particular person, but I don't need to know that where that particular person lives, from which server this email has been sent. So there are some complexities or there are some details which needs to be hidden, which are unwanted, or which are some internal details which needs to be hidden, and DBMS helps us to achieve this. So this was all about the advantages of DBMS. So with advantages, there always come some disadvantages, as coin always have two faces. So let's see the disadvantages of database. So the very first disadvantage of database is cost. So acquiring, deploying and sustaining DBMS software can incur significant cost. So obviously if we are sustaining a database, if we are deploying a database, that would be a very costly thing. Furthermore, the hardware essential for proficient operation of database management system can also lead to substantial expenses. So basically whenever we want to maintain a database or sustain a database, there are many operations we need to do to that particular database, and then we also need a hardware which would help us to do that particular operations easily and effectively. So there is increase in the expenses. So database management system can lead to more cost. So that is one of the disadvantage of DBMS. Now the second disadvantage of DBMS is scaling project. Yes, in the advantage I told that we can scale the database management system projects, but there is also a disadvantage with that. Let's see. So when dealing with modest applications and minimal data storage requirements, adopting a comprehensive DBMS could introduce avoidable intricacies and additional burdens. In these instances, more streamlined data storage alternatives could be better suited. So consider I want to store data of only 20%, and I got a database in which I can store data about of 1000 people. So again, that is not making very much sense to me. Yes, that database is scalable, but I know that I only have to store data about of 20 people. It can be 22, but it would never be 100. So scaling projects or scaling, we can see that the projects which require some kind of minimal data storage and adopting a comprehensive DBMS could introduce avoidable intricacies and additional burdens. So if I am I just want a database which store 20 people information and I'm having a huge database, so that is also something which I shouldn't be needed and which would eventually increase the cost, and this will be which would eventually increase the cost, and this would again be a disadvantage of database. Now the third disadvantage is vendor lock-in. So once you have chosen a specific DBMS, it can be challenging to switch to a different one due to differences in the data formats, query languages, and other technical aspects. Then can lead to vendor lock-in where you are dependent on a particular vendor's technology and pricing. So consider right now I'm working on a MySQL database. or a database which uses SQL approaches, SQL query and everything, like relational database. Consider like after few years I want to switch to a NoSQL database, which basically stores data in key value pair. So there are some constraints that I can't move from this database to this database because of the formats, because the query being used, because like in this data is being stored in rows and columns, but in this the data is being stored in key and value pair. So there are many constraints which come into picture whenever you are switching from one database to another database. That also leads to one disadvantage of database. So as you can see on my screen, it is made up of two words, data and abstraction. So data basically is a collection of raw facts, and abstraction you can understand in simpler terms is hiding something. So whenever we are hiding some internal information or some internal details which a user doesn't needs to know, it is called as data abstraction. So first let's see the definition and then we will understand with an example. So basically database systems are built with complex ways of organizing data. To make it easier for people to use the database, the creators hide the complicated stuff that users don't need to worry about. The hiding of unnecessary things from user is called as data abstraction. Now let's see from an example. So consider that I am having a database. Okay, this is a student database. Now, I am concerned about what all data I am putting in the student database, like the roll number, student name and different things. But am I concerned about where this database is being stored in my disk? Which memory location this particular database is being stored? No. Like why it matters to me na ki where my database is being stored, in which memory location it is being stored, what kind of data structure it is using for being stored, like B trees or hashing. Like I'm not concerned about all those internal details or all those details which are not concerned to me. I'm just concerned about data at a higher level. I want to do some data manipulation, I want to do some insertion, I want to do some update in the data, but I'm not concerned about where my database is being stored, where the data is being stored in a particular memory location. So I'm not concerned with all those details. So this is data abstraction. The hiding of unnecessary things from users is called as data abstraction. So basically I'm hiding some unnecessary details or some details which is not very much adds a meaning to me. So that particular data or that particular information I am hiding from the user. So I am not concerned about where my data is being stored. I'm just concerned about what my data is. Is the data correct? Is the data consistent? Is the data doesn't have any redundancy? So for that particular things I am concerned, but where my data is being stored at a physical storage, what techniques they are using for optimizing, what kind of indexing is going on, for all those details I'm not like very much bothered about. So that is called as data abstraction. We are not very much bothered about details like what is the indexing approach we are using, what kind of data structure we are using for storing the data, at which memory location or disk the data is being stored. I'm not concerned about all those details. So basically this is called as abstraction. Basically we are abstracting something from the user. We are abstracting all those details from the user. User is just interacting with data at a higher level. So there are multiple levels of abstraction. So let's see about all those levels. So there are 3 levels of abstraction. Let's see about all those 3 levels. So the first level is called as physical level, which is, you can say, the lowest level. Now the second one is logical level. And the third one is called as view level. So let's understand about all these levels of the abstraction from an example. So first let's start with the definition and then we will be looking at an example and we will be understanding all these 3 levels from the same example. So first level is physical level. So this is the lowest level of data abstraction. It describes how data is actually stored in the database. You can get the complex data structure details at this level. So let's take an example. Again, the same example which I took in the last slide. So I am having a student database. Okay. Now this level tells me how data is actually stored. So consider I am having this student database. There are many datas in this particular table or the database. Now consider that this particular element or this particular database is being stored at a memory location, or you can say SSD, hard disk, anything. So basically it is being stored physically at a storage location. So in this physical level, we get to know that where the data is being stored. So at this level, now what you can do, you can also optimize your data. So how you can optimize your database is key. You can perform some techniques. You can use some data structures which will help you in proper optimization. Like there are B trees, hash map, and many things hashing. So you can use that particular approaches and that particular methods to optimize your database. So basically here you are just concerned about where your data is being stored. In a simpler terms, so I am having a student database and I am only concerned about where the student database is being stored. Simple. Now going to the logical level. So basically logical level, can you relate with the term logical? So whenever we are doing something logical, some logical operations are being performed, like creation of a database, adding some constraints into database, identifying what is the relationship among the data elements, like these all things are taken care in the logical level. So this is the middle level of 3-level abstraction architecture. It describes what data is stored in database. So here basically it was all about how data is stored, and in this level we were concerned about what data is stored. So basically coming to the same example, now I know that there is a student database. Now I am making some tables. Consider there is a student table. Consider there is a table with student fee details or something like that. So there are multiple tables for student table which is having details about their first name, last name, roll number, and etc. Student fee details where they are having all the details about when they paid the fees, what were their fees, and how much money they have paid together, like some details like this. So basically at logical level what we do na, ki we make some tables like student, we provide some data to them, then we establish some relationship among them, or we identify that what is the relationship between the student name or student roll number or the student fee details and various things. So basically all the logical things like creation of a student table, then addition of some attributes, addition of some tuples in that particular student table. So attributes basically means columns, tuples basically means rows. So addition of some rows and columns into the student table, then providing a unique identity that consider that ID. So ID is something which is unique, not all the students would be having the same ID. So providing some constraints, and like much more things are done at a logical level. So basically in logical level we are not very much concerned about where our data is being stored or what all things. We are just concerned about what data is being stored. Okay, so the very third level is the view level. So highest level of abstraction is called as view level. This level describes the user interaction with database system. So again taking the same example, now consider there is a student database, right? So consider I am a teacher and my friend is someone who is working in the accounts team. Okay, so as a teacher I would need some details of student like roll number, subjects, student ID, and as someone who is from account team they would need details like student fees, paid in the month or month, like these details. So according to the need I can have multiple tables. Like if I am someone who is from the account team, I am majorly concerned about what is the student fee details, in which month they have paid, till which months they have already paid, till which month it is pending, like all those details which is needed to me. At a teacher level, I would be just concerned about what the student name is, what additional subject they have taken, or what is their roll number, or what is their student ID. So in the view level, what happens na, ki there are multiple there are multiple views which we can see, and which gives us you can say which gives us the opportunity to only see that particular data which concerns to me. Consider that I am in a school, right? So my principal can see all the data related to student, related to teachers, related to staffs. Now coming to teachers, teachers can see all the data related to students. Now coming to students, student couldn't see any data, right? So firstly, we will start with schema and then we will see what is instance. So schema. A schema is a logical container or a structure that organizes and defines the structure of a database. It identifies how data is organized, what data types are being used, what constraints are applied, the relationships between different pieces of data. A schema acts as a blueprint for the database, ensuring data integrity, consistency, and efficient data retrieval. So let's understand from an example, okay? So in programming terms, we always give like int a. So what does this mean? A is a variable which is stored at a memory location and its data type is int. So we can only store integer type values in A, and A is stored at a particular memory location. Now in A we can give the value as 2, either we can give the value as 3, either we can give a value as 21, we can give any value which would be integer, but A remains at the same place at the same memory location. So in the same way, what is schema? Schema is basically now a blueprint of the database. So consider I am creating a database of customer. Okay. So for this, what I need to do is first I need to make a customer table. So we will be first making a customer table. Second, I need to give some rows and columns in this particular customer table. Okay. At the third place, what I'll give, that I will give some field names or some column names and provide the data type they can hold. Now in the fourth number, we will be defining the constraints in that particular DB. So let's see. So basically consider that this is my customer table. Now customer table would be having some rows and some columns. So right now consider it is having 2 rows and 3 columns. Okay. Rows is 2, columns is 3. Now consider that they would be having some column names as well. So consider I am giving this column name as ID, this as customer name, and this as customer address. Okay. Now I have given the rows, I have given the columns, I have given the names to the column. Now I need to provide the data type. So ID would be something which would holding an integer value. Name would be something which would be holding a character value, and address the same character value. And we can provide the size as well for the same, like consider 8 digits, 14. Okay. So I have given the data type and I have given the limit of that particular data type. Now ID is something which would be unique for all the customer because it is generated at the time of, you can say at the time of billing, or at the time of we are feeding the entry of customer into our table. So ID is something which is very unique. So we can provide, or we can say this ID is a primary key for my table. So it is a primary key. So basically constraints in DB, all these things we have done in this particular schema. So now in ID, I can like give any value. Either I can give 1, 2, 3, I can give 4, 5, 6, I can give 7, 8, 9. I can give any value which would be of type integer. So basically I am giving a blueprint of my database here. So schema is a blueprint for the database which ensures data integrity. Like I can't put on any value which is apart from int in this customer ID. Data consistency, that my data remains constant throughout all the databases or throughout all the table. There won't be any duplicacy. And efficient data retrieval. So if I am having ID, I can retrieve the data for any of the customers. Now here we have defined the data types. We have defined the constraints. We have defined the relationship between different pieces of data. So this is called as schema. Now there are various types of schema. So let's understand about that. So types of schema. The first schema is called as physical schema. Are you getting something? In the last set of videos we discussed about physical level in abstraction. So it is kind of similar to physical level of abstraction. So physical schema. In a physical schema, it defines how the data is stored on the underlying hardware, including details such as storage format, file organization, indexing methods, and data placement. So basically in physical schema, now we basically deal with the physical terms like where my data is particularly stored. So in physical schema, I am concerned about where my data is stored on the hardware or disk or any memory space. So consider that my data is stored at this particular memory. Okay. So at this particular memory space, my DB is stored. Now I can see some of the methods of storing the data in the database. Like I can use the hashing method, I can use the B-tree method. Like there are many methods, there are many indexing methods which we can use, so that when we are querying and when we want the data, there should be a proper optimization which is established. So if I use like the file organization techniques, the indexing techniques, indexing methods, indexing techniques, then I could get my data very easily and very effectively, and it can also help in optimizing the data, and also these methods would help in the storage optimization as well. So in the physical schema, we basically deal about how the data is stored in the hardware or in the disk or in the memory space. Now what are the characteristics of physical schema? So it primarily lies in enhancing the storage and retrieval of data to boost the performance. Again, the same thing which I told in the last slide, that we make sure that we put the data in a proper place, in a proper storage or in a proper memory, so that it can be very easy for us to retrieve that data, and also it could help in the storage optimization, which would eventually lead to boosting of the performance. Now the second one is modification means to the physical schema demand meticulous planning and can potentially affect the overall performance of the database. So basically consider that my database is at one particular location. Now I am moving that database to another location. Then again I need to be concerned about how the data is being stored, what all methods of indexing we are using, how the data is being stored, how I can retrieve the data, what is the time it is taking for the data retrieval, what is the storage optimization. So there are many things. So if there are some modification made to the physical schema, it could potentially affect the overall performance of the database, because right now the data is stored in such a way that it gives me the higher performance, it takes lower time and gives the higher performance. But there could be a chances that if the modification is made, it could take more time, which could lead to a lower performance. Now the example, deciding to use clustered index on specific columns for a faster retrieval. As I told that we use some indexing methods. About all these indexing methods we would be knowing in the coming videos, but you just understand in a way that there are many methods. We use some of the methods to on specific columns for getting the data as fast as possible. Now the second schema is logical schema. A logical schema defines the database structure from a logical or conceptual perspective without considering how the data is physically stored. Now in the physical schema, we were majorly focusing on how the data is stored. Now here we would be focusing more on what data is stored. So I'm not concerned about wherever my data is stored in the memory location. I am mostly concerned about what kind of data is being stored. So logical schema is of two types. First one is conceptual schema and second one is external or view schema. See, all these terms we have already read in the abstraction video, the types of level. So it is kind of similar to that, but still I'm trying a lot to make you understand again that what all these terms basically mean. Now the types of logical schema. So the first one is conceptual schema. The conceptual schema represents the overall view of the entire database. It defines the high-level structure and relationships between all the data elements. The example which I told in the schema, that we are making a blueprint of all the columns, all the rows. We are giving some data types to these particular columns, like ID can have only integer values, name can have only character values, and like this. So basically we are defining a database, we are making tables, we are making rows, we are making columns, we are giving the data types, we are identifying the relationship between them, and we are also adding some constraints like ID is something which is unique for every customer, so that can be a primary key. Again, for the keys we will be knowing about it in the next set of videos, but just understand in a way ki something which is unique, something which can't be like something which shouldn't be twice or shouldn't exist twice. So consider that there is a customer ID. So every time whenever you are generating a customer ID, it will be a random thing. So one time my customer ID could be 1, 2, 3, one time it could be 4, 5, 6, it could be 7, 8, 9, but again it couldn't be 1, 2, 3. So there won't be any case where customer ID which is generated for every person, consider it is generated for A, it is generated for B, it is generated for C. For D also the customer ID remains the same, which is of A. It won't be possible. So there are some constraints, there are some columns, there are some rows which we define for a particular schema. It would be a better word to call. So for a particular schema we define everything. So in conceptual schema it basically depends on that what are the relationships we are giving for that particular schema, what is the number of rows, what is the number of columns, what is the data types. Now the second one is external or view schema. An external schema defines the user-specific views of the database. It focuses on the portion of database that are relevant to specific user, roles or application. So consider that there is a database of customer. Okay. Let's take an example of an e-commerce website. So in e-commerce website there would be many tables. One table would be of customer. Second table would be of orders the customer had made. Third table would be the prices for all the things and then discount and everything. So there would be 3 tables present. Like there would be many tables, but I am just taking an example of 3 tables. So consider I am a person who is working in the sales team of this e-commerce website. So if I am working in the sales team, I would be mostly concerned about what all prices customer has paid, what is the total amount the customer has paid, what was the total discount it got, how the sales are increasing, and much more things. So I would be mostly concerned about some specific table. If I am someone who is like seeing the analysis like what all things customer buys and how I should recommend the customer to buy the same thing, I would see the orders table. So basically according to the users we show different tables or we show different views. So in this view schema what we do is there are different views, and according to the user specifications, like I want to see the sales, I want to see the data related to customer, I want to see the data related to what all orders customer place and different things. So in this way there are different views, and these are user specifications on which the views are shown. So in this schema basically it defines the user specific views of the database. So basically here it is a customer, here it is an order, and here it is a price table. Okay, so there are some characteristics as well of logical schema. So it delineates how data is structured into tables, the interconnection between these tables, and the restriction placed on data. Again, the same thing that the data could be only of type integer, what all relationships are between the tables, and what are the number of rows, number of columns, and much more things. So basically it delineates how the data is structured into the table. Now second point is logical schema prioritize data modeling and database decide over considerations related to hardware or storage specifications. Again, we don't need to be much more aware about like how the storage, where the data is being stored or something like that. I'm not concerned about that. I'm basically concerned about like how my database is being designed, how much tables are there, how much rows are there. I'm mostly concerned about what data is stored. I'm not concerned about how my data is being stored in the memory space. Example, defining tables, specifying primary and foreign keys, creating views for the data access. So these are the examples for logical schema. Now the last term in this video is instance. So what is an instance? The information residing within a database at a specific point in time is referred to as database instance. So consider that today I made a database. Okay, it is a customer database. So right now I am having 3 customer 1, customer 2, customer 3. Okay, so I am having a database of customer 1, like how many orders the customer has made, like orders the customer has made. Consider that this customer has made, just give me a second, let me make a bigger table for you. Okay, so this is a customer table. ID, number of orders, and I can give the address. Okay, so ID is 1, number of orders is 2, address is Delhi. ID is 2, number of orders remains 5, and ID is address is Bangalore. Okay, so there is one customer which is having an ID 1. The number of orders they have made, total orders is 2, and they reside in Delhi. The ID is 2, the number of orders they have made is 5, and the address where they reside is Bangalore. Now there could be a possibility na ki right now I am living in Delhi, but what if I switch to some other place or some other state like Karnataka? So right now I am working in Delhi, but I have changed my job, and right now I am going to Karnataka. So I am relocating to Karnataka. So I would request the website, like we can take an example of Swiggy. So right now I am in Jharkhand, that is my hometown. I am making orders on Swiggy. I am giving my address. Now I am switched to, like I have came to Bangalore. Now I want the order delivered to be delivered at my Bangalore's address, right? So I'll make some update ki okay, right now that was my home address, but now the home address is the Bangalore one. So there would be some update in the database regularly, right? So at an instance, consider at this particular time, this is the data which is stored in the database. There would be some modification made in coming days. So the information residing within a database at a specific point of time is referred to as database instance. So basically the data which is there in my database at the specific point of time is called as instance. Within a given database schema, the declaration of variables within its tables pertain to that specific database. The term instance in the context denotes the current values of the variable at a particular moment in time for the database. So at an instance, the value of address is Delhi, but ho sakta hai after 2 days the address is changed to Bangalore. So at a particular instance, the address is Delhi, but after 2 days, if that particular specific time, if we see, the address could be Bangalore. So in this context, it denotes the current values of the variable at a particular moment in time for that particular database. So schema is basically a physical representation of database or a blueprint of database. Instance is the value of database at that particular specific point of time. So basically, database management system architecture refers to the structural framework and organization of database management system. How we are just organizing our database, like what are all the elements of the database we are using. Consider that I am designing a database system. So how many elements I would be using, how many clients would be there, how many servers would be there, how many databases would be there. Like there are many things, right? Whenever we design a system, we majorly be concerned about what all databases would be there, what all clients would be there, what all servers would be there. So basically it helps in organization of a database management system, that is DBMS architecture. It also defines how the various components of the system work together to store, manage, and retrieve data efficiently. So basically in this DBMS architecture, now there are like different types of DBMS architecture existing. We would be mainly knowing about 3 architectures. In simpler terms, you can understand that DBMS architectures help us to achieve a way in which we can organize our data, store our data, access our data, we can manage or we can organize the database systems, we can manage how many clients would be there, how many servers would be there. According to our requirements, we can select the tier level of databases. So basically, according to the user level, you can select any kind of databases, either it be 1 tier, either it be 2 tier, either it be 3 tier, or either it be n tier. Basis on your requirement, you can select any of the tiers of data. So let's understand about the types of DBMS architecture. So there are basically several types of DBMS architecture. Choice of architecture basically depends on the factors such as type of database, that could be relational or NoSQL, and the specific needs of the application. So it mostly depends on how my application is. Like if I am having a website which is handling so much of traffic in a single day, so I would be using a database in which I can achieve scalability at a good level, right? So there are many user requirements, there are many organizational requirements according to which we select the database. So there are three architecture basically about which we would be learning in this video. There are more architectures ahead, like centralized architecture, n-tier architecture, and much more. But here we would be knowing much more depth about the 3 tiers of architecture. So the first one is 1 tier architecture, the second one is 2 tier architecture, and the third one is 3 tier architecture. The 1 tier, 2 tier, and 3 tier, you can see that 1, 2, and 3 are being used. So it is kind of related to the database designing or the database system which is present for these level of architectures. So let's see for the 1 tier architecture. So in the 1 tier architecture, the entire database application, including the user interface, application logic, and data storage, resides on a single machine or computer. So basically, whenever you have the database installed in your computer and you are accessing that database for, consider that whenever you are learning SQL, you are performing some SQL queries, you are seeing the result, you are making some data, you are making some table, and on that tables you are manipulating or making any type of query. So you are making that query in your system, right? So client, user interface, and database, if all the three are in the same system, it is called as 1 tier architecture. So here you can see that data storage resides on a single machine or a computer, and the three things are the user interface, application logic, and the data storage. So basically, an example could be an illustration of straightforward single tier architecture can be seen when you install a database on your system and use it to practice SQL queries, as I told. So basically, this is the file server, and this is a PC tablet or anything. So basically, in my PC tablet, I just installed a database software and I am using it for making some SQL queries. So that is called as 1 tier architecture. Now coming to the 2 tier architecture. In 2 tier architecture, the presentation layer runs on a client, that could be PC, mobile, tablet, etc., and data is stored on a server. So basically, 2 tier, there would be two things, right? In 1 tier, there was only one thing, like the client, the user interface, the storage, everything resides in a single entity. But here there would be two entities. The 2 tier architecture provides added security to the DBMS as it is not exposed to the end user directly. It also provides direct and faster communication. So let's understand from the diagram as well. So as you can see, this is a 2 tier architecture. This is a client 1. And this is my client 2. Now this client 1 and this client 2 are interacting with this server, which is a database. So here you can see na ki there is a presentation layer, or there is a layer of security, that this particular client and this particular client are making requests to this database. Right, so there are multiple clients who are making requests to a single database or a single server, you can say. So there are multiple clients and they are making requests to a single server. So 2 tier basically means there would be two entities. First one is a client entity, second one is the server entity. The client is making some requests to the server, and the server is making some manipulations and doing some manipulation and returning that as a response to the client. So you can consider an example of a workstation where there are multiple computers and all can query into the same database and work with the same database. So there are multiple computers, there are multiple clients, and they are querying to same server. So this is a 2 tier architecture. So basically, just to give you an overview, in 1 tier architecture, the client as well as the server used to reside in a single entity. And in the two-tier architecture, the client and a server used to interact using a layer. So this is the basic difference, that in one tier, the client, the server used to be in a single entity. Like if I am installing a database software in my system, so that is a one tier architecture, because I am installing it in my system. I am using that to make multiple queries, but that particular server couldn't be used by any other person or any other person. Like it can be only accessed on my laptop. No other person who is having a different laptop can access that particular server, right? So that is like in my computer, I am having a software, I am using that software, I am making some SQL queries, and it is giving me results. Now when I switch to two-tier architecture, there might be multiple computers who would be reaching towards the same server. This is also called as client-server architecture. Client is like computer, PCs, tablet, and server is where our database resides. So basically, three-tier architecture, what happens? As the name suggests, 3 tiers. So there might be 3 levels of layers, or 3 levels would be there. So basically, it separates the application into 3 logically distinct layers: presentation, application, and data layer. So basically, what happens at 3-level architecture? Now, there is a distinction, there is a layer separation. The first one is a presentation layer, the second one is the application layer, and the third one is the data layer. So basically, there are 3 levels of separation of these layers. Like the first layer is like the client layer, the second layer is the application layer, and the third layer is a data layer, or you can say all the databases are present there. So basically, let's understand about the layers, and then we will see with a diagram and understand about this architecture. So basically, presentation layer, it handles the user interface. So basically, whenever we go to any website, consider we are going to Swiggy. So whenever we see Swiggy on our website or see Swiggy app on our mobile application, what we see? We see a page where all the menus are present, all the restaurants are present, all the food items are present. So that is called as UI. So whenever we are accessing any of the website, either through app or through web, we get a UI, which is the front end of the application, where we see every details, like the orders, like my what are the restaurants which are onboarded, what are the food items which are present. So basically, that is called the front end. So basically, in the presentation layer, that is also called as front end layer, we basically deal with the user interface of the application or the like website. So in example, you can see your PC, tablet, mobile, etc. Now the second layer is application layer. So it manages the business logic example server. So basically, what happens now? Now we have seen the UI. Now consider I am at swiggy.com. I want to order some food. So for ordering some food, what I'll do, I'll select particular restaurant. I'll just add it into my cart and I'll just place the order. So there would be some kind of business logic, or there would be some kind of logical operations which would be going on, like the addition, like the deletion of that particular thing from your cart, or the addition of particular thing in your cart. So there are some manipulations which are done. So basically, all that logics now that take place into logic layer or the application layer. Now the very third layer is the data layer. As the name suggests, it would be something related to database. So basically, it manages data storage and processing. Example, the database server. So it basically, what database does is store our data, manage our data, and do some processing on that particular data. So on the data layer, there is a database where all the managing of the data, processing of the data, and all other things takes place. Now let's see the diagram of this particular architecture, and we will get a more good overview about this architecture. So basically, as you can see, there are 3 layers: client layer, server layer or application layer, and data layer. Now, in the client layer, we basically deal with the UI, which is called as user interface. So basically, consider swiggy.com. So whenever we open the app, we can see some restaurants. And then whenever we open that restaurants, we can see their menu, then some food items and etc. So this is the landing page. So basically, that is called as UI or user interface. Now in the second layer, consider I am I am like having a craving of eating chocolates. Okay, so what I'll do, I'll go to Swiggy Instamart and I will add some chocolates into my cart. Okay, so basically whatever I am doing, the addition, it is kind of a logical operation, and that is happening at an application layer. Now at the very third layer, what is that? That is a data layer. So in the data layer, if I am adding something to my cart, there would be a database with called as orders. So in that orders, this particular thing would be feeded. So there would be a storing of data, also processing of data. So all these three things now take place, and all these three things like the presentation layer, application layer and data layer, they are not dependent upon each other. They have different infrastructures. So we can like make application more scalable by using by broadening this particular layer or another layer or different layers. So basically they all have their own infrastructure, so we can broaden our application, we can scale our application accordingly, because one layer doesn't affect the other layer. So we can make changes at one layer, we can use the scalability principles and much more things to scale our application. So all of them have a different infrastructure. That is why the 3-tier architecture is the most used architecture, because again here we are getting an extra security of the application layer where all the business logics is happening. The client layer is not directly talking to the database layer. There is an application layer in between, and like there are much more things. We can scale our application, and there are many advantages. So we would be seeing about the advantages in the next slide. Okay, so this is the advantages of 3-tier architecture. So the very first advantage is, as I told, the scalability. So basically it is easily to adjust each tier to handle changing user demands. As I told that each tier have their different infrastructure. So if we are having any kind of user requirements, we can do any kind of manipulation at any layer which won't affect the another layer. Now the second thing is modularity and maintainability. Simplifying maintenance by separating responsibilities. Again the same thing, that the client layer has other responsibilities. It is responsible for the UI. The server layer or the application layer is basically responsible for all the logical operations which is happening, and the data layer is mostly responsible for all the processing which is happening in the database and also storing the data. So all of the layers have their different responsibilities, so it is very easy to maintain. Now the third point is security. Protect sensitive data with an additional layer. As I told that there is an additional layer of application layer, and client is not directly interacting with the database. So there is an additional layer of protection which helps in the security purpose and also in the scalability purpose, as none of them are dependent on each other. Performance, optimizing presentation and application tiers for better performance. As I told that we can optimize any of the layers, but they are not dependent upon each other. They have their own infrastructure, so we can optimize them according to the user requirements to get some better performance and better optimization. Now with the advantages, always there comes a disadvantage, because every coin has two faces. So let's see the disadvantages as well. So the disadvantage of 3-tier architecture, it includes increased complexity. Obviously there has been an introduction of an extra layer which is doing all the logical operations. So the complexity is kind of being increased as the level of tiers of architecture increases. Now the second thing is potential latency issues. So you might find some of the latency issues as well, because there are 3 tiers of architecture and there might be some issues which would be encountered. Consider there could be issues like when we are talking to the database layer, there could be issues in manipulating the data, there could be some issues in processing the data. There are many potential issues which could be encountered while doing any manipulation at any of the levels. Now the third thing is longer development time. Again, 3 tiers are involved. So at one level you need to code all the logic, that at one level you need to design the front end of the application, then at one level you need to design the back end of the application. So the development time increases, because again the client is not directly talking to the database, it is talking it via application layer. then resource overhead and possibility of bottlenecks. Because of complexity of the database, there are much more things which are being introduced, because this is a bit complex tier architecture, so there might be like complexities which could arise in each and every moment of time. Again, longer development time because of 3 tiers architecture, then overheads, then there are many things, latency issues, overhead, bottleneckings, and much more things which is involved, because of which these are coming as a disadvantages of 3 tier architecture. But it is kind of mostly used in the companies and mostly used everywhere, because 3 tier architecture is a place where like you are dealing with the front end client layer, you are dealing with the back end data layer, and you have an additional layer, application layer, where all the business logics is being happened. So if you want to change some business logic, or if you want to do some alteration, you don't need to do alteration at all the levels. You can just go and alter, like update or alter anything at the business or application layer. So that is the major thing, that it is helping us to there is a layer by layer protection. Also, it is helping us to achieve optimization. It is also helping us to achieve scalability at a very good level. So that is why 3 tier architecture is mostly used. So data model. A data model within a DBMS, that is database management system, serves as an abstract representation of how data gets structured and organized within a database. It outlines the logical arrangement of data and connection between various data components. So it also plays a vital role in comprehending and shaping databases, acting as a vital link between real-world entities and actual storage of data within databases. So we read more about definition. Now let's see what is exactly data model. So let's understand what is flowchart first. So people who would be doing programming, they would be having a slight idea about flowchart. So in flowchart, what happens is we give some instructions, like consider I don't know how to make Maggi, right? So I am making a flowchart on how to make Maggi. So basically in the flowchart, the very first thing would be to boil the water. Now the next thing would be to put noodles and masala. And much more thing. We are not here to learn how to make Maggi, but there are much more things, right? So we can consider it as flowchart or algorithm also. Okay? So there are many steps which is involved in making the flowchart as well as algorithm for making Maggi, right? So if we have the flowchart or if we have the algorithm with ourselves, it would be very easy for someone who doesn't know how to make Maggi. They can follow that particular instructions or follow that particular steps and make Maggi. So basically in this way only, flowchart helps very much. And data model is kind of, you can consider it as a flowchart, where we get to know about like what all data would be there, what all relationship between the data would be there, what all constraints would be there, what are the attributes, what are the entities, and much more things. So let me just erase all these things. Okay, so now let's understand. So basically in the last lecture, we learnt about schema. Now here it is data model. Now in data model, what we do is we deal with datas, then the relationship between data, and then the constraints. Okay. Now in schema also, you would have heard I said some similar sort of thing, that it is kind of a blueprint of a database where we are dealing with data, relationship, and constraint. So you would be having a doubt, then what is the major difference between schema and data model? So data model is a conceptual framework. Or you can say an high level view. High level view of database. So basically in data model, we have a conceptual framework, or it is a high level view of database. Like there is a database, there would be such data in that particular database. The relationship between the data would be that. The constraint in the data would be that. So like there is a conceptual thing which is going on. Okay, so in a very high level, we tell that what is the data, what is the relationship between data, what are the constraints present in the database. But in schema, what happens na? Ki schema is the implementation of a data model. So if I provide a data model, I can do the implementation using schema. So in schema, we basically do the implementation of the data model. So as I told that if you have a flowchart or algorithm of how to make Maggie, and if it is provided to you, you can make Maggie very easily. So in the data model, we provide a very high level view of our database, and in schema, it is basically implemented using all the given data, then the data, all the given information, and then there are data, then there are relationship, and then there are constraints. So data model is a conceptual framework or a very high level view of the database. Schema is basically the implementation of the data model. So there are various types of data model. So let's have a look. So one is hierarchical data model. The next is network data model. The third one is relational data model, which is very widely used. The fourth one is ER model, which is again very important from the point of interview and from the point of semester exams as well. Then the next one is object oriented data model, and the last one is NoSQL data model. So let's have a look about all these data models. So the very first data model is hierarchical data model. Are you remembering something? We heard about hierarchical inheritance, right? So basically hierarchical data model is somehow taking all those concepts, and we would be seeing that here as well. So in this particular model, it portrays the data in a manner that it is resembling like a tree-like structure, where each record maintains a parent and child relationship. Its primary application lies in older database system. So basically in this particular model now, as we learned in hierarchical inheritance, so basically there is a parent-child relationship which is maintained. Each child would only have one particular parent. So every child would be having only single parent. There are no more parents for a particular child. So basically as you can see that here there is a child. The parent is school. So let's start from the top to bottom approach. So school is a parent. Now school is a parent, so it might have some childs. So now department and infrastructure are its child. Now coming to department. Now it is the child for school, but it might be a parent for its child, which is teacher, student and staff. So you can see there is a parent-child relationship which is maintained all throughout, and any of the child is not having more than one parent. So basically in hierarchical data model, there is a child which is having a single parent, and there is a tree-like data structure which is maintained. So this is kind of used in very older database, you can say as XML database, and it's not used very widely. But there is an enhancement of this particular database. So let's see the enhancement. So basically the next data model, which is also an enhancement to the hierarchical model, that is network data model. So this model shares similarities with the hierarchical approach, permitting records to hold multiple parent-child relationship. So there could be multiple parent-child relationship. One child could have many parents, one parent could have two childs, like there are multiple parent-child relationship which is maintained. It adopts a structure like graph, as you can see. A structure like graph is obtained, offering more flexibility compared to the hierarchical model. Again, in this particular model, one parent can have many childs and one child can have many parents. So in this particular model, there is more flexibility in compared to the hierarchical model. But again, this particular model is also not very widely used. So let's learn about the data model which is like very widely used. So the next model is the relational data model. About these data model, I guess we learned in the starting videos itself, but let's understand again. So organizing data into tables known as relation consisting of rows and columns characterizes the relational model. It stands as the most prevalent data model rooted in the principles and of the set theory and relies on structured query language for data manipulation. So basically, what is database? Database is kind of collection of interrelated data. So what does this term means, interrelated data? So interrelated data means when data, like when the table are somehow interrelated with each other. Consider there is one table which is having details about student first name, last name, roll number. Consider second table which is having details about student subjects, then the co-curricular activities and much more things. So these two data have a relationship among them. They are mostly related to student only, student information only. So whenever there is like relation between two tables or two, you can take it in this way, table 1 and table 2. So whenever there is a relationship between two tables, it is called as relational data model. Now basically it uses the structured query language for making queries like manipulation of data, insertion of data, deletion of data and much more things. Also this relational data model is most widely used. Here you can see this particular table is also called as relation in database, rows which is also called as tuples, and columns which is also called as attributes. And here there is a constraint which is called as primary key, which is a unique identifier. So this is a table which is also called as relation. That is why this is called as relational data model, because somehow there is some relationship between different relations, that is different tables. So collection of interrelated data is database where there are many tables and all those tables have some relationship between them. So that is why we call this as relational data model. Now the fourth model is the entity relationship model, which is called as ER model. So it basically deals with entities and their relationships. Entities is also called as objects. So basically this data model is utilized for crafting relational databases. The ER model represents data through entities, attributes and relationships connecting these entities. So consider student is an entity. Now student might have some relationship, student studies, student is a enrolled student and much more things. So basically the relationship which is defined here is study. Now student does study. Now student may have some attributes, like may have some properties. Key student have like student name, student roll number, student address and much more things. So that is called as attribute. So basically it is student name, which is a attribute like the property of the student. Entity is basically a single object. You can say student is an entity, or any real world entity or object could be used here. And then relationship, that what it does and what the relationship it has with other people as well, other things as well. So basically student might have a relationship with course, which is course is also altogether a new entity. So there might be some relationship, so that is represented here. Then there is entity and then there is attribute, which is basically the entity properties. So the next data model is object-oriented data model. So object-oriented data model basically extends the principle of OOPS, that is object-oriented programming, into database domain, and this model depicts data as objects complete with attributes, methods, fostering support for inheritance and encapsulation. So consider that you have your front end which is written using OOPS. Now you want a backend which would be compatible with OOPS. So there this particular model come into picture. So it basically stores data in form of objects, and also it uses the object oriented programming principles. It is also helpful in achieving inheritance and encapsulation. Also in object-oriented data model, basically it is kind of a combination of object-oriented data model plus entity relationship data model, because in entity relationship data model, entity is treated as an object. Here also data is treated as an object. Now the next and the last data model is NoSQL data models. So basically in the NoSQL databases encompass a diverse array of data models such as document oriented data model, that is MongoDB, key value data model, that is Redis, column family, that is Cassandra, and graph, that is Neo4j. These models are designed to offer scalability and flexibility when handling extensive volumes of unstructured or semi-structured data. So basically, NoSQL database models are something in which we don't use the SQL database for making queries. Also, we don't use it doesn't follows any traditional approach of relational data models. So in this data model, the data is stored in the form of key value pair. The complexity is a bit less, and also it is very scalable and can be used anywhere. So most popular NoSQL database which everyone uses is MongoDB. It is like very widely used, and it is also very helpful to fetch the data because again it is stored in key value pair, which is also using hash map for storing the data. So data independence is basically a fundamental concept with database design and management, emphasizing the distinction between the logical and the physical dimensions of data storage and administration in a database management system. This principle yields various benefits such as enhanced flexibility, heightened security, and simplified maintenance. Now, do you remember in the schema video as well and in the abstraction video as well, I told you about some levels like view level, conceptual or logical level, physical level. So if you are not remembering it right now, I have a picture about that as well. Yeah. So this is the diagram for the same. So basically, let's understand what is data independence and how it is helping us to achieve more flexibility and higher security and much more things. So basically, in data independence, what happens na, ki as you can see from the term data independence, so somehow we are making user independent of the data. So basically, data independence here means na, ki at any level, either it be physical level, either it be logical level, either it be view level, at any level, if there is any change, it won't affect the other levels. So basically consider that there are three levels: physical, logical, and view. Physical level basically deals on where the data is stored. Logical level basically deals on what data is stored. And view level basically deals on, you can say, virtual tables or views based on user requirements. So basically this is a brief about all the three levels. So in the physical level, we are majorly concerned about where our data is being stored. In the logical level, we are basically concerned about what data is being stored. And in the view level, according to the user requirements, we see some kind of virtual tables. Consider like I am working in a factory, right? So there would be many people in the factory. One would be a salesman, one would be someone who is looking into some other details in the factory. So for like each member, there would be some different database which would be shown to them. Also, we can take an example of library. Consider in library, there are many people, there are students, there are then library staffs, then there is a person who looks into all the databases. So for the students, there would be some data which would be visible. For the librarian, there would be data like when the student issued that particular book, what is that particular book, what is the price of that book, and much more things would be visible. And for the library, for the person who is looking mostly into the database or a higher level authority, they would be having access to the librarian data as well as the student data. So according to the requirements, like if I am a student, I want to see these particular fields in that particular database or that particular column in that particular database, so I can see that according to my user requirement. If someone who is a librarian, he or she wants to see that which student issued which book on which particular date, what is the price of that book, what is the student ID, and much more thing, he or she can see that. So basically in the form of virtual tables, we get to know data according to the user requirements. So this is about all these three levels. So here data independence, what happened na, ki data independence says that if there is any change at physical level, there won't be any impact at the logical level. So if we are making any change in the physical level, the logical level won't be impacted. So basically this is also called as physical data independence. So in physical data independence, it says that any change which is happening at the physical level, it won't affect the logical level. Let's understand it from an example. So let me just erase everything and then we will see the example. So yeah, okay, so physical data independence. So consider that let's take an example of book. Okay, so there is a database of book. Okay, consider that right now it is stored in a hard disk. The database is stored in a hard disk, like the number of books which is available at a particular library. Now consider one day, since there is like lot of database, we thought to move it from hard disk to cloud storage. So basically earlier the database used to reside in the hard disk, but now the database has been migrated to cloud storage. Like you can also take an example of like various e-commerce platforms. So some e-commerce platforms or some e-commerce companies which used to exist 20 years earlier and are existing now as well. So they might have some data. So it sounds very vague na ki from 20 years they are using the same source for their data storage and everything. They might have migrated it to some different places. They might have opted some new techniques for data optimization and much more things. So basically whenever we are doing this migration from hard disk to cloud storage, there is no effect which is seen in the logical level. So basically whenever we are doing anything on the physical level, logical level is not affected, and that is called as physical data independence. So basically any data change, or like any data change I can't say, but any thing which happens in the data, like the data storage has been removed from one place to another, or any change which is happening at a physical level won't affect the logical level. So this is called as physical data independence. Now the second one is logical data independence. So basically in logical data independence, what it means ki if any change is there in the logical level, it won't affect the view level. So basically in logical level, what could be the changes? So basically in physical level, we deal with where the data is stored, and in logical level, we basically deals with how the data is being stored, like in the form of tables, rows, column, how many columns are there, what are all are the constraints, and much more things we deal with. Consider that again I am taking the same example. So I have a book database, right? Now in the book database, I have different factors such as book ID, book author. So right now I am taking these two columns into consideration. So I have ID and I have book author for this particular book database. Now consider I want to know more about like what are the types of books, like are there any thrillers, or are there any books which deals into drama, and much more things. So I want to know about the type of the book as well. So what I'll do, I'll add a new column, type. So basically what I did, I added a new column which is called as type. Okay. So since I have added a new column, there is some kind of change which is happening at logical level, but it won't affect the view level. How? So consider that earlier I wanted to see the ID and book. So I was doing a select ID, book author from book. Okay. And now again, if I like this was before achieving logical independence, before achieving logical, and again after achieving logical, if I run the same query, I would be seeing the same data, right? So according to the user requirements, we are modifying the data, but consider that there are two users who are querying into the database, user 1 and user 2. So if user 1 is making any change, user 2 is not affected by this change. So that is basically ki whenever we are doing any changes in the logical level, like addition, modification or something, it's not affecting the view level at all. So this was all about physical data independence and logical data independence. I hope you got a slight idea about what is data independence. So I'm just reiterating everything. Data independence basically mean at any one of the level, if we are making any change, it does not affect the upper levels or the higher levels. Now there are two types of data independence. First one is physical data independence, second one is logical data independence. In physical data independence, if we are making any changes to the storage or like where the data is residing, or like much more things are there, but again I'm taking the example of only storage of the data. So if we are storing the data at a particular place and we are moving the data to next place, it doesn't affect the logical level. And in the logical level, logical data independence, what happens ki if we are making any modification at the logical level, consider addition or modification of any columns or change in the any constraint, it won't affect the view level. So basically data independence helps us to ensure that at each level, if any change is happening, it is not affecting the others level. So in this particular video, we would be looking more on the essential components of table. So again you would be saying ki why you are teaching us what is row, what is column, but again there are some words for rows, some words for column, and much more things. So let's look at it, and then we will start with all the ER models and then the SQL queries and much more things. So basically the very first term is row or tuple. So basically the row, like in table what we say is ki this is a table. Okay, so these are the columns and these are the rows. But consider that someone asks you like what is the value or what are the elements present in this particular tuple. It might sound confusing na sometimes, because we generally remember these terms rows and columns. We don't know what is tuple, we don't know what is attribute. So in like this particular definition, we are definitely gonna learn ki row is also called as tuple and column is also called as attribute in DBMS. So basically rows are known as records. See, we got a third name as well, right? So first is row, second is tuple, and third is records. So rows are also known as records or tuples, and it represent individual entries or instances of data within the tuple, within the table. So basically again, if we are inserting any individual entries for some particular columns, like consider name, consider class, consider roll number. So if we are giving some individual entries for everything, that is a row, like the place where we are giving individual entries in the table. So there is one more term which is kind of can be asked in your online assessment test of like 1 mark, or in your like semester exams as well, because like again people tend to forget the name like tuple for row and record. So there is one more thing which is cardinality. So basically what is cardinality na? The number of rows in a table is called as cardinality. Consider that this is my table. Okay. So this is the table I have. Consider it is a book table. Now someone asked me what is the cardinality of this table. So what I'll do is I'll count the number of rows. So this is R1, this is R2, this is R3, and this is R4. So altogether the cardinality becomes 4. So cardinality is basically the number of rows in the tables. Now the second term is columns or attributes. Again, the column is a name which is a very generic name, so we tend to remember, but attribute is something we tend to forget. So column is also called as attribute. Column represent the attributes of the data being stored and are named to describe the information they hold. Consider like ID, name, and age. So basically columns are basically the attributes the table is having. Like consider that I am a person, I may have some attributes like I may have a ID, I may have a name, I may have a age, I may have a roll number, and much more things. So basically all the attributes of mine I can store it in table, in the column, in the tables. So basically column represent the attributes of the data which is being stored and are named to describe the information they hold. So consider that there is a table, consider, okay? So now I gave here Riti, okay? I should have made a bigger table. Okay. So this is a table, and here it is Riti, and here I have given 99372 dot dot dot. Now, can you understand what is Riti and what is 99372 dot dot? So basically what we do is na ki we give a attribute name. So basically this is the name is Riti and phone number is this thing. So basically whenever we define any attribute for all the entries which are feeded in the row, that is called as column. So again, as we read about cardinality in row, there is one thing which is called as degree, which is also the number of columns in a table. Okay, so T is a typo. So number of columns in a table is called as degree. So basically for this case, the number of columns are C1, C2, C3 and C4. So overall the degree becomes 4. So basically cardinality is the number of rows, degree is the number of columns, rows is also called as tuples or records, column is also called as attributes. So you can remember all these terms. Now coming to the next slide, this is a table which I have taken for reference. So basically you can see these are all the rows or tuples. These are all the columns and attributes. So iske bare mein to we got a clear understanding what is rows and what is columns. But what is this term primary key? Like what is this primary key? So primary key is something now which uniquely identifies the table. So let's look at it in the next slide. So basically keys are at number 2, but let's see with the constraint and then we will come to keys. So what are constraints? So constraint define rules or condition that must be satisfied by the data in the table. Common constraint which include uniqueness, nullability, default values and much more things. So consider I am making a table. Okay? In that table, there could be some fields which could be null. There could be some fields which couldn't be null. Consider that I am making a table about person and I am mentioning I am making Aadhaar card of a person. Okay? So in the Aadhaar card of person, I want name, I want the first name, I want the last name. Okay? But middle name is something which a person may have, may not have. So that column could be null as well. So we can set ki theek hai, this column can be null. But the first name and last name is something now which is required. So we have to mention ki that columns are not null. So we put a constraint that these columns are not null and this column can be null or something. So these constraints help us na ki even if I am feeding any data and if I forget to put the first name of a person and I just put on the last name, it will give me an error or it won't, it will show a error in the database itself. So consider this example which I told right now. So for Aadhaar card details, I have the first name, I have the last name and I have the middle name. So this is something which can have null values, but these both are something which cannot have null values. So these particular type of things, these particular type of checks whenever we put on in our database, that is called as constraint. It basically ensures that we are not putting any kind of data in the database. There are some constraints which we need to follow whenever we are putting data into the database. So there are many constraints. First one is the unique constraint, which ensures the value in a column are unique across the table. So if there are values in a column, consider ID. So I need to take care that ID is something which should which should remain unique for all the entries which are there in the database. So for that case, unique constraint comes into picture. Now the second one is not null constraint. As I gave the example of this Aadhaar card, ki first name and last name couldn't be null, so we put a not null constraint. Now the third one is check constraint, which enforces a condition to be true for each row. So there would be a check constraint that consider there is a person and for them voter ID can only be made when they are above 18 years. So there would be a check on the birth date that check if the birth date is above 18 years, then only we can make the voter ID of a person, otherwise we cannot. And the fourth and final one is default constraint. So it provides a default value for a column if no value is specified. For this, what example I can give you? Okay, so consider that, okay, consider you are in nursery class. Okay, so you might have a name, you might have some date of birth, and you might have a section. Okay? And consider in your school there is only one section, that is nursery A. So what it will do na, ki it will feed the name, it will feed the date of birth, but when it comes to the section, there is only one section A. So what we do is ki we make default as A. So if I somehow left this particular field which is not filled, so basically it will take the default value and it is feed it as A. So default values, what it ensures ki if the column is not having any values, they would be having a default value as this. So like these all terms are na, you can understand from the very first thing. First name of this, unique, so something very unique. Not null, so something shouldn't be null. Check, so there is a check on true or false, or if there is a condition and we are checking it on the basis of that. Default constraint, something default we are putting a value. So from the very first letter you can understand the meaning of all these terms. Now the very last is keys, which I showed you here as well, this primary key. Now what keys help us in? So key, what basically it does now, it ensures that there is uniqueness in our table. So basically a primary key is a unique identifier for each record. Record is also called as row. So each record in the table, it ensures that each row can be uniquely identified and accessed within the table. So what does this mean? So consider I am having a table. Okay. Now I am having a table as name. I am having the table name. Okay, let me make a big table now. So I'm just making a more big table. Okay, so this is name, this is consider address, and this is consider phone number. Okay. Consider there are twins, okay, and both of them have the same names. So consider that I and my twin both are having the same name as Riti, and we both live at the same place, that is Bangalore. And the phone number is also same for both of us. Now, since we are twins, I know we might have same name, we might have same address, we might have same phone number, but there would be something unique between us. Na? Matlab, there would be something unique ki this particular person is considered having a roll number 1, I am having a roll number 2. Or there should be something unique which could like at least identify my entire entries in that particular table. Like it is for Riti 1 or it is for Riti 2. So basically what primary key does na, ki consider if I add a new column called as ID, and here I give ID 1, ID 2. Now whenever I need to see data for Riti 1, but I am considering twins, but I am saying like whenever I need to see data for Riti 1, I'll just make a query based on ID. It will give me all the required data. Whenever I need details about Riti 2, I'll make the query based on the ID and it will give me the entire data for Riti 2. So there might be a possibility na ki many rows may have same data. ठीक है, मतलब consider you are having the same address and your sister is also having the same address. You are having the phone number of your father and your sister is also giving your sister or your brother is also giving the phone number of your father. So there might be a possibility that there could be same data which exists in the database. So for that thing, primary key is introduced, which uniquely identifies all the records or all the rows in the table. So it is basically kind of a unique identifier which uniquely identifies all the rows for a particular person. Or all the records for a particular person. Again, there are two keys, primary key and foreign key. Again, I'm not discussing in much depth about all like these keys. I'm just discussing about these terms because these terms would be used more and more from now, and you should be having a proper idea if I'm saying that it is a record. So you should be able to understand, okay, record is something which is called as a row, or if I'm saying tuple, then you should also understand, okay, it is a row or attribute column. So you should be having that proper understanding. Now, the second key is a foreign key. So a foreign key is a field in a table that refers to the primary key of another table. It establishes the relationships between two tables. Now consider that there are two tables, okay, and both tables have somehow data about me only. First table is having data about my name, my age, my roll number, and second table is having like details about my phone number and my address. Okay? So there are two tables which are having same data about me. What if there is one particular field ID which is there in table 1 as well and table 2 as well. So if there is a ID section in table 1 and table 2 which is kind of having similar data, we called it as foreign key. So foreign key is basically a field in a table that refers to the primary key of another table. It establishes relationships between tables. So basically it helps us to establish relationship between two different tables. So when we will be going in the query part and the SQL query part, or in the ER model itself, when we would be proceeding ahead, I'll be explaining about all these keys in very much depth, but it's just that for you to have a reference so that you don't miss out the next videos. So this was all about this video. I hope you like this video. This was a very beginner friendly video, so I hope you don't curse me for this. But again guys, see, I'm trying to like cover each and everything because it should be something which should be beginner friendly. Everyone would be able to understand the simple terms as well, right? I've seen my friends who are like very good at DBMS, but if they were asked in the interviews like tell me what tuples are there, the cardinality or the degree, they weren't able to say that, and it is a very minor concept now. So it throws an image on the interviewer that the person hasn't read it very well. So view is a virtual table that is derived from one or more underlying tables. This means that it doesn't physically store data but rather provides a logical representation of data. So from the definition, it is evident that view is something, it's not a table which is already created. It's kind of a virtual table. So if I need some data about like ID, a student ID, student name and student roll number, and I have a database in which there is student ID, student name, student roll number, student subject and much more things. So I can just create a view and I can just get all the data which is necessary to me. So basically views is also called as virtual table. Like the table is not created in the memory, but we get all the details through this virtual table. So in views, what happens now? We see the table according to the user requirements. Now consider I am having a e-commerce website. Consider a shopping website, okay? So let's just feed some data here. So ID is 1, name is Rahul. Phone number is consider XYZ, address is Bangalore, PIN is again I am giving some random values 192, and age is 18. Now here also I am giving some data, here also I am giving some data. Okay, so basically I have this database which is called as customer database. So I am having a customer database. As I am running a e-commerce website, there would be a database in which all the things would be stored. So consider that there is one customer, customer 1. It places an order in my website. Now what it will do is it will generate some ID for that particular customer. It will feed the name, the phone number, the address, the PIN and the age of that particular customer. Now consider that there are many teams in this shopping website. One is the team which is logistic team. One is a team which basically looks on the marketing and different other teams. Okay, so consider there is one person from the marketing team, name Ajay, and there is one person from the logistic team, name Vijay. Okay, just a rhyming word. So basically Ajay is a person who is majorly focused on the marketing of the website and the shopping website, and Vijay is a person who looks on all the logistics like the order delivery, if the order is placed correctly or not, if the order has reached particular person or not. So there are two persons. Now consider that Ajay want to see some details about the customer. Now Ajay is a person who is from marketing. So does it make sense that I send the age of the person, or I send the PIN of the person, or I send him the like address of the person, like I am creating a table, he's making a query in the table. So does it make sense that all these 3 fields are something which would be something concerning to him? It won't. There would be another field. Consider, just give me a second. Okay, yeah, actually there's no space. Okay, just forgive my bad handwriting. Consider there is one more column in the table, that is order. So consider that this person orders some top, this person orders some tea, and this person orders skirt. So Ajay, basically from the marketing team now, he would be more concerned about how I can raise the marketing, how I can raise the sales. So what I'll do, if a person is someone who orders tea most of the time, I'll show him most of the ads regarding the tea. I'll filter his search, and like there are much more things which I can do to increase the marketing. But again, am I considered about the age of the person? Am I considered, somehow age is also considered, but am I considered about the pin of the person? Am I considered about the address of the person? Or am I considered about the phone of a person, phone number of a person? No, I am not. So basically I'm from marketing team. I just want what type of order this person makes, and age to some extent, because I can see, I can like filter some of the items for a person who is above 18, some of the items for a person who is less than 18. So mostly I'm concerned on that particular factors. So what I'll do, I'll make a query in the table, and it will show me 2 columns only. First one would be the, okay, just it's 2 columns only. So first one would be the order, age. So basically order and age is something which I am mostly concerned about. Now consider Vijay is a person who is from the logistic team. Now the logistic only needs to know what is your name and what is your address, along with PIN and everything. But if a person is from logistic, is he concerned more about your age? What would he do after knowing your age, right? It doesn't make any sense to him to know your age, right? He's more concerned about like what type of orders you have placed, what is the address of yours, what is the pin code of yours, so that the order could be delivered at time. But he's not he's not very much bothered about your age and much more factors. So views and virtual table, what it does now, it shows me the fields, it shows me the table according to the user requirements. So if one person is from marketing, one person is from logistics, so in the marketing person will see all the fields which is concerned to him. The logistic person will see all the fields which is concerned to him. But it's kind of a virtual table. A new table is not created from the existing table. It creates a virtual table which shows me all those data, but the database remains unaffected. So basically this is view. So view, basically views or virtual tables is something which shows us all the required details according to the user requirements. So this is a small very small concept in DBMS, but people tends to get confused on this views in DBMS. So again, reiterating the same thing. Views or virtual table is basically the logical representation of data where we see data according to the user requirements. If a user is from some particular team like marketing team, he would be only more considerate about the data which deals with marketing, like orders, then the age and much more things. And if a person who is from logistic team is more concerned about the address, pin code and much more things. So basically keys in DBMS make sure of data integrity, uniqueness and quick retrieval of information. Key is an attribute in a table. So let's understand from an example. So consider that this is a table which is a student table. Okay. Now in this particular table, let's have some rows and let's have some columns. So I am having 3 rows and 4 columns. So let's just name them. Let's name it as ID. Let's name it as name. Then let's give it as registration number. And let's provide this as address. Okay. Okay. So like if you remember in the earlier videos, I told you that the rows and columns in the particular table is also known as, like the rows is also known as tuples or records, and the columns are also known as attributes. Okay. So basically what is happening here is that we have taken a student table. In that particular table, there are some of the attributes or some of the columns which are like ID, name, registration number and address. So let's fill in some data here. 122 name, let's consider just a random example A, and here address I am taking it as XYZ. Okay, so what is happening here is that there is 3 entries or 3 records which is present in this particular table. Now what is key? Key is an attribute in a table. So this is a student table, right? So in this student table, what are the attributes? Let's list that down. So first attribute is ID, second attribute is name, third attribute is registration number, and fourth attribute is address. So basically these all are keys. So key is basically an attribute in a table. Now there is one more thing what we have seen here in the definition is keys in DBMS make sure of data integrity, uniqueness and the quick retrieval of information. So how keys are playing role? So consider that I want like all the details of a person whose ID number is 1. So if I make a query in the database with give me the person whose ID is 1. So if I'm making that particular query, what will happen? I'll get all the details of that particular person or that particular student which is present in the database. So it will help me for a quick retrieval of data, because again I don't need to provide whose ID is 1, whose name is this, whose address is this. So all these attributes or all these properties I don't need to define. I can just get the data with a single property. So keys always help in quick retrieval of information. Now coming to the uniqueness part. So like in the further slides you will see about candidate key and primary key. So what is uniqueness? Now consider taking this example only. Here you can say ki the person who is having ID 1 is also having name as A. The person who is having ID 3 is also having name as A. So there could be a possibility that 2 persons can have same name, right? Or 2 students can have same name. So if 2 students are having same name, and if you're making query based on name, which data it will show? It can show any data, right? But you want a data of student whose ID is 1. So if you make a query with the use of name that give me the particular details about a person whose name is A. So you might get this particular data as well, or you might get this particular data as well, right? So but to get a concise data, to maintain the uniqueness in the table, there is a concept called as primary key which comes into picture, which we will be seeing in the further slides. But just to make you understand, key ID is something which would be unique. Okay, so student A is having an ID 1, student B is having ID 2, and student A, like the name is A, is again having an ID 3. So ID is something which is not duplicated, or there is not duplicate data which is present in the database. So ID is something which is always generated whenever a student record is being fed, or ID is something which would remain unique for all the students. So ID is something which is helping us to maintain the uniqueness in the table or the database. So and data integrity. So data integrity is something like if you have some integrity constants which are present, like consider that ID is something which is giving me uniqueness or providing me uniqueness in the table. What if I put an ID as null? So there are some constraints we put that this particular field can't be null, this particular field should be unique, this particular field should not be null, or this particular field should be null. So there are some unique constraints we put, on the basis of which we can always feed the data in the database. So if consider that I am if consider I am making this particular attribute ID as not null, so I can never leave that ID. If I leave that ID and fill in the data or create a query to insert the data, it will always throw an error. So there are some constraints which are being introduced to maintain the data consistency, data integrity and much more things. So keys are helpful in maintaining the data integrity, then the uniqueness and then the quick retrieval of data. Now let's jump into type of keys. So basically here I have listed down 4 types of keys. First one is candidate. Second one is primary key, third one is foreign key, and fourth one is super key. So let's have a quick look through on all these keys and understand it with an example. So now the very first key is the candidate key. So you often have heard this term primary key like in many prior videos of mine, but you haven't have heard this term of candidate key. So let's understand what candidate key basically means and how it is helping us in what is the proper significance of candidate key. So basically, a candidate key refers to a group of attributes that are capable of uniquely identifying record within a table. Among these, one is selected to serve as a primary key. For example, consider for student all the possible attributes for candidate key could be student, this is a table where ID is a attribute, roll number is an attribute, Aadhaar card is an attribute. So let's understand from an example itself. So there is already a table which is present. Let me just create one more. Okay. So again we are jumping back to the same example which we have seen in the last slide. So there is a table student which is having ID, name, registration number and address. Okay. This is the same example which we used in the last slide. So right now I am not filling much data. I am just giving again some random values. And here let's keep it as okay. So I have just put on some random values in this particular table. Now this is the table. So let's list down this table entities. So student is the table. The attribute of students are, student table is ID, then the name, then the registration number and then the address. Okay. So these all are the attributes of the student table. Now in this attributes, there are some of the attributes, as I told in the earlier slide, ki ID is something which uniquely identifies records in the table. So there might be some of the attributes which would help us for a uniqueness, to maintain a uniqueness in the database. If that particular key is or that particular attribute is present, if I make a query in the database using that particular attribute, like suggest if I'm making a query in the database using ID where the person ID is this, or if I'm making a query in the database using a registration number ki the person registration number is this, so it will provide me a uniqueness. It will uniquely identify all the records. All the records means all the records which are present for student. Consider there are 3 records which are present for student. So there is an attribute using which if I make a query in the database, it will uniquely identify all the records in the table. So basically, what is candidate key? Candidate key basically refers to a group of attributes which are which uniquely identifies records in a table and which can be served as a primary key or a possible option for being a primary key in the table. So here I have listed down all the attributes. Now see, name is something, again there could be duplicate names. There could be 2 person with the name Rahul, or there could be 2 person with the name Raj as well, right? So name is not something which can uniquely identify records in table, because again 2 person can have the same name. Now coming to the third thing is registration number. Now registration number is something which is generated at the time of admission. So every person who is taking admission would be having a unique registration number. So registration number is something which could help me to uniquely identify all the records or all the rows or all the details which are present in my table. So registration number is a possible option for a candidate key. Now coming to address. Now address is also something like 2 people can have, address is also an attribute which have lots of things like the street, the pin code, the area and much more things. So area is something which could be similar for 2 person. Street could be something which could be similar for 2 person. Obviously house number is not something which could be similar, but again area is something, street is something. Address is something which is further divided into many subsections, right? So for now I'm not considering address as a possible option for candidate key, but again address could be, but again it's you have to feed the entire address for that particular person, one person who lives in street A, house number this, area this and state this with pin code this, right? So here there could be 2 possible options. First one is ID and second one is registration number. So ID and registration number is something which could help me to uniquely identify records in the table. Let's not make it as let's make it street. Okay, I guess now some doubts are clear. So I thought address was something which was confusing. Now street. So street is also something which could be same for two persons. So I can't make that street as a possible option for a candidate key or a group of attribute which can uniquely identify records in the table. So here we have possible options as ID and registration number. So for me, the candidate keys are ID and registration number. Explaining in one word, candidate keys are the group of attributes which are possibly helping us to uniquely identify records in a table. And again, in that collection, we choose a primary key from that particular collection only for our table. So this is candidate key. Now the second key is primary key. Okay, so primary key is like most important. It would be used many places, at many places. It might have been used in the earlier videos as well. So understand it very clearly. I guess candidate key, if you have understand, primary key is very easy to understand. But let's just have a look at what is primary key and then let's understand it from an example. So primary key is a key which uniquely identifies records in a table. Again, there were some keys which we find out. First one was ID, second one was registration number, which was helping me to uniquely identify record in a student table, right? Now, it ensures that each tuple or record can be uniquely identified within the table. Now, this line is very important. So, it is always unique plus not null. So, primary key is something which would always have a constraint of unique plus not null. As again I explained in the earlier slides. Key, if consider that I am making ID as a primary key in this particular table. Okay. So ID is a primary key. Now I am feeding the record for all the particular, for all the students which is present in my like task list or wherever Excel sheet. So I am feeding all the records of that particular student. Consider that while feeding, I left ID for a student, like by mistake, I didn't fill the ID. So it will throw me an error because again I am saying that ID is something which is serving as a primary key. So it should always be not null and it should always be unique. What does unique means? Unique means none of the two person can have the same ID, and not null means that particular field can't be left or that particular field needs some value. So basically, starting from keys are something which like attribute of a table. So keys are basically attribute. Now coming to the candidate key. So candidate key is a group of attributes which uniquely identify records in a table. Now coming to primary key. So primary key is a key from all these group of attributes. Now from all these group of attributes, there are attributes like ID. Consider that there is an attribute called as phone number. There is an attribute called as Aadhaar card. Let me just type it. So consider that there is a student table. So since student is a like vast table, it would be having many information like student ID, student name, student subject, student fee details, student phone number, student address, and much more things. So right now I'm just considering few of the things. So consider the student table has ID, Aadhaar card number, phone number, and registration number. Okay. So these are all the group of attributes which are possible or which are an option for candidate key. Now consider like start from ID or start from Aadhaar number. So basically ID would always be unique and there is no place that ID could be left null, right? So ID is a good possible option to be a primary key, right? Now consider Aadhaar number. Nowadays, the government of India has made it mandatory to have an Aadhaar card for everyone. But there could be a possibility that one of the student doesn't have an Aadhaar number or one of a student doesn't have any PAN number. Like let's consider PAN number as well. So there could be a possibility that one student has a PAN number, one student doesn't have a PAN number, right? So it is somehow violating this fact that it should be unique and it should be not null. I can't make the PAN card number field as not null, because many students can have PAN card, many students can't have PAN card, right? So PAN card or Aadhaar card is something can't be right now considered a possible option for primary key. Yes, they qualify for being a candidate key, but again for primary key they doesn't qualify because there is always a constraint which is there, that is unique plus not null. Now coming to phone number. Consider that a parent has two children and both of children are going in school for studying. Both of them are in the same class, and then again they are giving the phone number. Now their father's phone number would always be same, right? So two fields would have same value. Again, it is somehow violating the unique plus not null constraint, right? So it cannot be a possible option for primary key. Now coming to registration number. As I told that registration number is something which is generated at the time of admission, right? So every student would be having a unique registration number. So registration number is something which can qualify for a primary key. So either of them can be a primary key, right? So basically coming from keys is keys is basically attributes of the table. Candidate key is basically group of attributes which uniquely identifies records in a table, and primary key is a key which uniquely identifies records in a table having the constraints such as unique plus not null. So if an attribute or if a key has a constraint which is unique, which is not null, it is a primary key. So now the third key is foreign key. So what is a foreign key? A foreign key is a field in a table that refers to the primary key in another table. It establishes a relationship between two tables. So what is foreign key? Foreign key is basically a key in another table which acts as a primary key in the prior table. So let's understand from example. Consider that there is two tables. First table is the student table, second table is the subject which the student has opted for. So the first table or the table which is being referenced is called as reference table or base table, or the table which is like kind of referencing from other table is called as referencing table. Now here the student table has the attributes such as roll number, name and hometown, and here the subject table is having attributes such as roll number, name and subject. Now can you see this roll number which is present here as well and here as well, right? So there is a roll number which is present in referencing table which is called as foreign key because it was a primary key in the base table. So basically a foreign key is a field in the table that refers to the primary key of the other table, and how it helps in establishing a relationship against student and subject. There are two tables and they have a relationship between them. Student studies a particular subject, like the student name is this and the subject he has opted is maths. So basically in student table and in the subject table there is a kind of relationship which is being established, and there in the relationship or in the referencing table, like there is a table from which we are taking a reference and we are making other tables. So basically from student table we can make like many tables, right? There would be many tables which would be referencing from the student table. Consider a subject table, consider a fee table, or consider other tables as well, right? So there will be many tables from that particular base table, and there would be some relationship of that base table with the referencing table, and in that referencing table the attribute which acts as a key is called as foreign key because it is being referenced from another table. So basically foreign key is a key which acts as a primary key in the reference table. So basically this is all about foreign key, a field in a table that refers to the primary key in another table. So basically what is happening, it is referencing this particular attribute. So here for this student table, roll number is the primary key, and for student table in the subject roll number is foreign key. So I don't want to extend the video very long. I guess it has been more than 20 minutes the video has gone to. So let's discuss more about foreign key, candidate key, primary key, in the coming videos. We would be also discussing about super keys, and we will be solving many questions to understand in depth what is candidate key, how it is helping, how it is providing a possible option for primary key, and much more things. There are so many numericals as well. So I'll pick 2 or 3 and we will solve that numericals as well. So this was all about keys in DBMS. Just to give you a summary, key is an attribute. Key is like you can say that all the attributes which are present in a table can act as a key if they provide uniqueness, if they ensure data integrity, and if they ensure the quick retrieval of data. Now coming to candidate key is a group of attributes which could possibly be served as a primary key, or group of attributes which uniquely identifies record in a table. Now coming to primary key is a key which uniquely identifies record in a table, but there is a constraint that that particular key or that particular attribute which is be chosen as primary key should always be unique plus not null. And foreign key is a key which is basically acting as a primary key for another table. So basically these are all about the keys. So here we are seeing foreign key, but I want to re-revise the concepts of last as well. So basically what is key? Key is basically an attribute in a table. So any attribute in a table is called as key. Now what is attribute? So if there is a table, there would be some rows, there would be some columns. So basically all the columns is called as attributes, and all the rows are called as tuples in a table. So basically attributes. So key is any attribute in a table. Now what does keys help in? Key help us to maintain the uniqueness in the table. Key help us to maintain the data consistency in the table, and key also help us to get the faster retrieval of data. So basically keys helps in many ways. Now next we saw a concept called as candidate key. Now what is candidate key? Candidate. Now as I told na ki key might have 3 properties. First one is key, it ensures uniqueness. Second one is key, it ensures faster retrieval of data. And third is key, data consistency. Okay. Now in candidate key what happens na ki candidate key is basically a set of attributes which can uniquely identify records in a table. So what does that means is ki consider that there are attributes. Consider that this is student ID, this is a student table, there is a student ID, there is a name, there is a Aadhaar card, and there is a phone number. Okay. So now in this table, ID is something which would always be unique for every student, right? Like consider that there is one student. So for him the ID would be generated and it will always remain unique. Now for the next student also ID will always remain unique. Now for the next student also. So these all rows are also called as records. So for all the records the ID is something which remains unique. So it can be a candidate key. So it qualifies to be a candidate key. So in this candidate key, this candidate key is basically the set of attributes or the set of keys we can say, and here the ID is one of the key which help us to uniquely identify records in a table. Now the second one is name. Name is something like two persons can have the same name. So name is not something which can uniquely identify records in table. Consider that there is two persons who are having the name as Rahul, and consider that I am making a database query based on the name of a person. So consider I am making a query ki select star from table where name is equal to Rahul. Now which Rahul data it will give me? It can give me some inconsistent data, but I want the data of a Rahul whose ID is 1, whose Aadhaar card number is any 50040 something like that. Okay. So we are here providing some details, or we are here trying to fetch the details of a person whose ID is 1 and whose Aadhaar card details is given. So if I get the details of another Rahul, it is like the incorrect information which I am getting. So basically name is something which can remain same for different people. So name is not an attribute which would qualify to be a candidate key. So for name we would discard this. Now coming to Aadhaar card. Again, Aadhaar card is something which is unique for all the people. So it will be unique for all the records in the table. Using the Aadhaar card, if you are making the query, we can fetch the details correctly and there would be a uniqueness. Like for, if I'm giving Aadhaar card number of a particular person, I would be only seeing data of one person, not two persons. So basically Aadhaar card helps us to uniquely identify all the records in the table. So Aadhaar card can also be a part of candidate key. Now the next one is phone number. Again, phone number is something like it can be unique for every person or every person which is present in the record or every student which is present in the record. So phone number can also be a possibility to be a primary key. So here we can give phone number. So basically candidate key is a set of attributes which can qualify to be a primary key, or the set of attributes which uniquely identify records in table. Now coming to the third key, that was primary key. Now what is primary key? Primary key is a key which uniquely identifies all the records in the table. Now you would be saying ki candidate key also does the same. There is a set of keys which uniquely identifies all the records in the table. Then how come I can select a primary key? So basically primary key is being selected from all the set of attributes which is mentioned in the candidate key. So from all these three attributes, one can be primary key. Now let's see that which one can be a primary key. So now consider ID. Again, ID is something which is generated whenever a student take an admission. So ID is something which won't be, okay, there is one more constraint for primary key, that any key which is having unique plus not null constraint can only be a primary key. So any key which is having unique value, also null value shouldn't be there, because again it can't uniquely identify the records in the table. So any key which is, or any attribute which is serving as unique or which is having the constraint as unique plus not null is only qualified to be a primary key. Now coming to ID. ID is something which is generated every time the student takes the admission. So basically ID is a good qualification for primary key. Now coming to Aadhaar card. There could be a possibility na ki few of the people don't have Aadhaar card number, like they haven't registered for the Aadhaar card yet. Few people have the Aadhaar card but few people don't have the Aadhaar card. So for them the Aadhaar card attribute or the Aadhaar card column would be null. And again what we told, that primary key is something which is not null. So it won't be a good option for being a primary key in the table. Now coming to the phone number. Consider that there are two students and they both are siblings. Now they would be filling the details of their father phone number, and father phone number is something which could be same for two people as well, because 2 or 3 students could be there who are having the same father or they are siblings, right? So phone number is also not something which will uniquely identify, because there is a possibility of duplicacy, and again it will then destroy this unique constraint. So phone number is also not something which will qualify for a primary key. It can qualify for a candidate key but it won't qualify for a primary key. So at the last, ID is something which becomes our primary key. So in short, key is something which is attribute of a table. Candidate's key is a set of attributes which uniquely identify record in a table and which can also qualify to be a primary key. Primary key is a attribute which uniquely identifies record in a table. Also primary key is something which is unique and not null. So any attribute which is having unique plus not null constraint is only qualified to be a primary key. So this was all about candidate key, primary key and keys. Now we will look on foreign key. I'm just re-revising the concept because referential integrity is something which is related to foreign key, but just a revision because it is keys in DBMS. So basically foreign key. A foreign key is a field in a table that refers to the primary key in another table. So basically what is foreign key? Foreign key is an attribute or is a field in a table which refers to the primary key of another table. So what is happening? There is two tables, right? In one there is a foreign key, in one there is a primary key. The table, consider that there are two tables. I'm just drawing table A and table B. Now consider table A is a student table, okay? And table B is a table which have all the details about students, like the course they have taken or the subjects they are studying, okay? So here there would be some columns, here also I would say the word attributes. So here there would be some attributes, here also there would be some attributes. Consider that here the attribute is ID, name and hometown, consider, okay? And here the attributes are ID, subject ID and subject. Now what is foreign key? So foreign key is basically a field in a table which refers to the primary key of another table. So basically in table A the primary key is ID. In table B, right now I'm not more focused on primary key, I'm more focused on foreign key. So foreign key is ID because ID remains same here and remains same here. So what foreign key is doing now, foreign key is kind of establishing a relationship between two tables. So table A and table B have a relation. So table B is having a foreign key which is pointing to the primary key of table A. Student and course are two tables. Student is somehow related to or have a relationship with course. They have opted. So course is having a foreign key and student table is having a primary key. Now student table which is being referenced is called as reference table, and subject table which is referencing other table is called as referencing table. So basically here table A is there, table B is there. Okay? Now let's take an example. What if these two are separate table, table A and table B are separate table. What if the foreign key in this table is ID, but could the primary key be also ID? Is it a possibility कि foreign key and primary key is same for table B? So there could be a possibility that the foreign key and the primary key for table B is same, but again like there could be a chances of anything. So foreign key and primary key for table B can be same as well, can be different as well. So it totally depends. But again, foreign key is something which should be present in the table we are referencing to, right? So reference table or the base table, if it is having a primary key in the another table to establish a relationship, it should always have that primary key which is present in the form of foreign key. So basically what foreign key does now, foreign key maintains referential integrity, which is the video all about. So I guess it's almost 10 minutes and we are now jumping to the topic. Prior was all the revision about keys and everything. I hope everything is revised because I really need you to understand keys in depth, and then we can jump ahead to referential integrity. So now coming to reference table and referencing table. So basically what is a reference table? Reference table is a table which is having primary key, PK, and referencing table is a table which is having a foreign key. So basically this table is having a foreign key which is basically pointing to the primary key of the base table. So this is called as referencing table and this is called as reference table. We would be using these terms all throughout this particular slides. So please be careful about what is reference table and what is referencing table. You can understand it in this way. Reference table is something which is being referenced from another table. So table B is referencing to table A. So table B is a referencing table and table A is a table which is being referenced. So table A is a reference table or base table. Now what is referential integrity in foreign key? So basically referential integrity now, let's just break this term. So it is referential integrity. So what does integrity means? Integrity means na same thing everywhere. So let's understand referential integrity from an example. Consider that you are hungry right now, okay? So you have 2-3 options to order food. Either you can order it via Swiggy, either you can order it via Zomato, either you can order it via Uber Eats. Like there are many options for you to order the food, or either you can order it from Domino's, Cloud Kitchens and much more. Okay. Consider you want to have a pizza. So consider in Swiggy the price for the pizza is 154 rupees after discount. The price of pizza in Zomato is 152. And the price of pizza in Uber Eats is around 150. So you can see that there are differences in prices in all the 3 apps, Zomato, Uber Eats and Swiggy. So data is something now which is not consistent in all the apps. The prices for the food differs in all the app. So basically integrity is something which is not maintained here, because again it all depends on the apps and the companies, that how much profits they are making, how much margins they are keeping on and much more things, right? So integrity is something which says us that there should be same data which is present everywhere for a particular thing. Like for a particular pizza, there would be a same price which is present on all the different platforms. But somehow it is violating that thing, because for the same pizza at different platforms, the price is not same. So basically what happens in referential integrity is referential integrity is an important concept in foreign key. We always say foreign key maintains referential integrity. What is the reason behind we saying that foreign key maintains the referential integrity? So basically, referential integrity ensures that the relationships between the table remains accurate, consistent and meaningful within a relational database. So referential integrity, what it says is, consider that right now I am a college student, okay? So I am a college student, Reeti, who is currently in the computer science branch and who is having a roll number as 14, okay? So if someone asks me in the entire college, if someone asks any person, get me the details of Reeti, who is right now in CSE branch and whose roll number is 14. So they would get the same data from everywhere. Like if they ask my data in the library, if they ask about my data in the admission corner, or if they ask about my data at other places as well. So the data remains the same. My name, my roll number, my ID, everything remains the same. There is no change in the data. So basically integrity is maintained here. So integrity means in any databases, if you are making any query, there is the same data which is present for a same person. So I guess referential integrity is something which is a bit confusing, but I've tried to break it into simpler terms and explain you. But again, in the coming videos, we would be looking on how referential integrity is being maintained in the databases, how foreign key is helping us to maintain the referential integrity. What if consider that there are two tables and referential integrity is something which is maintained in both the tables. Now consider that in one table we are inserting something, in one table we are updating something, and they are somehow related with the primary key and foreign key relationship. So what would be the effect on the tables and much more things. So there are much more things we would be looking in the coming videos. Basically you can understand that foreign key is something which maintains a relationship between two tables, and there are some set of rules which make sure that the relationship between two tables which is maintained is accurate, consistent and have a meaningful relation. So basically to ensure that thing, referential integrity comes into picture, and we have to see that what happens if we are inserting something, if we are deleting something, or if we are updating something from the reference table or the referencing table, how the referential integrity is taking place and what all violations of referential integrity could take place. Since there are two tables, consider there is a table student and there is a table course, okay? So now consider in the student table we have some set of records and some set of attributes. In the course table as well we have some set of records and some set of attributes. Consider here we have a student roll number, then student name, and then student phone number. And here we have the course ID, the course name, the roll number and the course details. So we have two tables, student table and the course table. They have some attributes such as roll number, name and phone number, and here course ID, course name, roll number and course details. For this the primary key is roll number, which will basically help us to uniquely identify all the records in the table or all the details about the particular student. And here the roll number is present and somehow student is related to course, like student is taking a course. So there is a relationship which is maintained, because consider now student, there is a huge database of student name, student phone, student address, student roll number, then what courses student has taken, then what fees student is paying, what is the attendance. So there is humongous data about student. So what we do is we split it into a tables. So basically this is a student table and this is having the details about all the courses student has taken. Now consider here I am giving some roll number 1, 2, 3, 4, and here also I am giving roll number 1, 2, 3, 4, and other fields right now I am leaving it as blank. So here basically roll number is the primary key. Now I want to establish a relationship between student and course. So what it will do is here it will mark this as foreign key. So what is a foreign key? Foreign key is basically a key which targets to the primary key present in another table. So basically it is somehow referring to the primary key in another table. So this is a foreign key. So basically a relationship is being established in this particular tables. So referential integrity help us to maintain this relationship. Referential integrity help us to maintain the data accuracy ki roll number 1 is here, so here also roll number 1 is here, the details are remaining the same. And data consistency, again if roll number 1 is somehow removed from here and here the roll number 1 is there, so data is inconsistent. So basically it helps us in these particular ways. Now the table which is being referenced is called as reference table or base table, and the table which is referencing to another table or which is pointing to the primary key of another table is called as referencing table. I should point the arrow like this. So basically this is a referencing table and this is a reference table. Now what if we insert some data in the reference table? What will happen to the referencing table? As this table is particularly not having much of importance without the student table. So what if in the student table we add some data? What if in the student table we update some data as well as delete some data? So what will happen in that particular cases? So we will be seeing case by case what happens and how we can ensure that these particular violations of rule, if happens, doesn't happen. So basically now consider there are two tables. One is referencing and other is reference table. So reference table, referencing table. Let's see how some operations like insert, update and delete works here. So referential integrity in foreign key, insertion in the referenced or the base table. So consider again I am making the same drawing. I'll make it a bit quick. So basically this is a student table and this is the reference table. Okay, reference dot base table. This is the course table. Now it is having field as course ID, course name and roll number, and this is also having fields like roll number, student name and student phone number. So I'm just filling 2 or 3 details. So 1, 2 and 3, student name Aman, Raj, Riti and phone number 00010002002. Here CID, course ID I am giving as 0102, course name DBMS, operating system and roll number is 1 and 2. So now I have made a tables and here it is a primary key roll number and here the same roll number is called as foreign key, which is pointing to this. Now we are talking about what happens when there is an insertion in the reference or base table. Consider that a new person or a new student takes admission another day. So I'll register his data or fill his data. His name is his roll number is 4. His name is consider Radha and her phone number is 022. Now if this insertion take place of roll number 4 Radha, does it affect this particular table? Think. No, it doesn't affect. So because student table or student database is a database now which keeps on increasing. Every year some new student take admission. In between the sessions also some new student take admissions. So right now in the course table I am having details about the students who have already taken admission and have already been assigned some courses. But since this particular student has taken admission newly, maybe he or she haven't been assigned any course yet. So if there is insertion here, it doesn't violate any of the rules or it doesn't affect this particular table because this particular table is having details of student with roll number 1 and 2. So roll number 3, roll number 4 or even if there are some more roll number 18 or 90 tak bhi, if there is some insertion, it won't affect the table. So basically if there is any insertion in the reference table, it won't be affecting the referencing table. Now the second one is deletion in the reference or the base table. So I guess it is a tedious task here to make table each and every time. So again I'll make it a bit quick. So this is a course table with CID, course name and course detail, roll number. And this is a student table with roll number, name and phone number. So this is basically the referenced or the base table and this is the referencing table. So it is having 1 2 3 1 2 3 and 0 1 0 2 0 3 and here 1 2 3 course name DBMS, just making it very fast, and name consider REF. So basically there is a person R, there is a person E, and there is a person F. So what happens if there is a deletion in the base table or the reference table? Consider roll number 3. He or she has passed out from the particular school or college, or consider that he or she had her father or his father had a transfer and now she need to leave the school in the middle of the session. So what happens when there is a deletion from the reference or the base table? Would it cause this particular table? Yes, it will. Why? Because see, here for roll number 3 we have entered all the details. Ki roll number 3 is having a course name, is being assigned a course, basically operating system, and is having a course ID 03. So basically if we are removing the roll number 3 all the details from the base or reference table, the referencing table doesn't make sense, which it will be pointing to. So basically here the foreign key is pointing to the primary key of this particular table, and if we are deleting any data here, so where it will point to? So basically it will consider I want the details for roll number 3. So this particular field will not give me any details, because it is only saying roll number 3 is having course name as this, course ID as this, but the student is not yet in the school. So if the student is not in the school, does this data make sense? No. So basically whenever there is a deletion in the reference table, we need to move it from the referencing table as well. We need to remove the data from the referencing table. So basically if any student has dropped out from the college or from the school, all the details, all the data which is present needs to be deleted. So it may cause violation if the corresponding data is present in the referencing table. So basically if the corresponding data which is removed from the reference table and is still present in the referencing table may cause some problem and may cause some violations. So to make sure that if some data is deleted from the reference table, it's not present in the referencing table, there are some methods and some tricks we can use. So let's have a look. So if a record in reference table is deleted or updated, the corresponding records in the referencing table should also be deleted or updated to maintain the integrity of the relationship. Basically integrity means data consistency, data relationship, data accuracy. So what we can do is we can use actions like cascade delete for the same. Also we can set null for the values deleted. So what it will do now, cascade delete, what it will do if some data which is being deleted from the reference table, what it will do, it will delete it from all the referencing tables. So basically if a person who is named Ram has dropped out from the college or from the school, if we delete his data from the student database, what it will do, all the other tables which are referencing to student database, they will cascade delete will delete all the data which is present in the other tables as well. So basically cascade delete is a method which we can use to ensure the integrity is maintained. Or what we can do is we can set the values as null for that particular student whose record has been deleted. But again there is a twist. Consider that in the referenced table, if a record is deleted and we set the value null in the referencing table, like consider null null null, what if this course ID is a primary key and we are setting the value as null here? So primary key can't be null, right? So this null method is something which is not very much used, or which I also won't suggest to be used, because again if you set all the values as null, what if any of the attribute is a primary key? So primary key can't be null, right? So you can use this cascade delete, which would really help to delete all the data which is present in all the referencing tables. Now the third and the last operation which is left is update. So updation in the referenced or the base table may cause violation, because if the corresponding data is present in the referencing table. So consider again we are having two tables. One is the referenced table and one is the referencing table. Now I'm just filling the data only for one field because it's an update operation, so I can explain with a one field only. Consider there is a roll number, student name, student phone number and student address, and here it is course ID, course name and course roll number. So consider roll number is 1, 2, student name is Ram, Raj, phone number is something, address is something, okay? Consider 012, 013, address is ABC XYZ, and here the course ID is 011, 012, 013, course name is DBMS OSCN, and the roll number is 1, 2 and 3. So consider that there is an update in the data. What happens if there is a person with roll number 3 named Riti, 014 and ZZZ. Okay, so what happens if roll number 2, which is Raj, has dropped out from the college or dropped out from the school? So what happens his data is deleted from here as well and there as well. What if Riti data, like now Riti is roll number, priorly Riti was roll number 3, but now Riti has been changed to roll number 2 as roll number 2 has left the school. So there is an update in the roll number, right? Consider that there is more update in the student name as well, like sometimes student give their half name or the first name only, but according to Aadhaar card or according to the board mark sheet they should be giving their full name or something like this. So consider that there is any update in the data which is happening at the reference table. So would it affect the referencing table? Yes, it would affect, because if we are updating the data here, the data should be updated everywhere. Roll number 3 is now having computer networks and having the course ID is 013. So roll number 2 data has been deleted. So basically, just like delete, in update as well, there is a command called as cascade update, which will update all the details for the particular person you are updating in the reference table. So basically for insertion, there is no violation. For deletion and updation, there is a violation. So we should be using on cascade delete, on cascade update to update in the all the referencing tables and delete it from all the referencing tables. What is a reference table and what is a referencing table? Referenced table and referencing table. So like you can understand it in a way na ki reference table is also called as base table. Basically, reference table is a table now which is being referenced. Like consider that I have made a table. It is taking reference from one table. So that particular table from which it is taking the reference is called as reference table. So basically, you can think in a way that the table which is having primary key is called as the reference table. Now the referencing table, the table itself which is taking reference from another table is called as referencing table. So here you can consider the table which is having a foreign key is called as a referencing table. So basically this was referenced and this was referencing table. Now in the last video we got to know what happens whenever there is a insertion, deletion or updation which is happening in the reference table. Now why we need to know this operations and what happens, like how all these things are related. So basically what happens na, whenever there is two tables, there is one table which is having a primary key and there is another table which is having a foreign key, which basically establishes a relationship between two tables. Now why this relationship between two tables is needed? So consider there is a student database, right? Now student database is such a huge database. If we consider there is student name, student roll number, student ID, student address, student subjects, there are much more things, right? So there would be some multiple tables in which there would be student information stored. There would be some tables which basically depends on student itself. So consider that a student has taken admission into the school or college. Now the student may opt some subjects, may pay some fees, may be a part of some club or different things. So club, and like if the student takes the admission, only then he or she can be a part of club. If a student takes admission, only then he or she can take a subject. So basically subject is a table which is called as a referencing table, which basically takes reference from the reference table. So consider here the reference table is a student table and here the referencing table is the club they are a part of. So basically referencing table is mostly dependent on the reference table. Referencing table has all the data which reference table, like basically in the reference table all the data which is present. In the referencing table you will get all the reference data for that particular person or for that particular student. So for that particular student, what is the club in which he or she is, what is the subject he or she has taken. So there could be multiple referencing tables for one reference table. So there is a relationship between reference table and referencing table. Now what happens whenever there is some CRUD operations which is being performed on the reference table and referencing table? So for the reference table, as I told you, whenever there is an insertion, deletion or updation, there are some violations or there are some rules which is broken in some cases. So what are these rules and why broken and violation means so much to us? So basically what happens now, let's start from the very beginning. So there is a reference table. Now there are some sub tables which acquire data from that particular table or that particular database. So there is a reference table called as student. Let's take it. So there is a reference table called as student. Now student is having so many referencing tables, like the club which student is a part of, subject, co-curricular details and much more. So basically this is a referenced table which is having a primary key, and then these are the referencing tables which is having a foreign key. Now these two tables may have a relationship between them. Now there is a term called as referential integrity. What does this term means? So basically referential integrity means, integrity means ki same data in all the databases. So what does this same data in all the databases means? So consider that there is a student Raj. Okay, so Raj is currently a CSE student or an IT student. Now in the college, whenever you will go to any of the cells of the college, like the placement cell, the admission cell, the library, the physics lab, the chemistry lab, everywhere, you will find Raj with roll number this and having a subject as CSE or having the branch as CSE. You won't find any data of Raj where Raj is studying in electronics who is having the same roll number. So basically in all the places, in all the databases, the data would remain the same. So basically integrity means same data everywhere. So referential integrity are some set of rules which ensure that the relationship between two tables have the data accuracy, have the data consistency and have the faster retrieval of data. So referential integrity are some set of rules. Now these set of rules may violate whenever you are doing any kind of insertion, deletion or updation in any of these tables. So basically we discussed in the last video about the reference table, what happens whenever there is an insertion, updation or deletion in the reference table. Basically in this particular video we would be mostly focusing on the referencing tables. So it was just a recap for what we have learned in the last video. I thought to give you that because if someone is new to this video won't understand what is the term referencing table, reference table and foreign key, primary key, referential integrity and much more. So let's start. So basically the first is insertion in the referencing table. So now let's make two tables. First one is a student table and second one is the subject student has taken. Okay, so here I am giving student a roll number, student a name and consider student a phone number. Okay, and here I am giving student a subject ID, subject name and here the roll number. So basically 1, 2, 3. There could be many more students. First is Raj, Riti, Rahul and phone number is considered 0012 0019 00067 and here I am giving as ID as 01, 02, 03, subject name as physics, chemistry, maths and roll number as 1, 2 and 3. So basically we have two tables here. First one is the student table and second one is the subject table. Now in coming to the student table, so student table has a field called as roll number. So roll number is an attribute which can uniquely identify all the records in a table. If I just make a query with the roll number, give me all the details of a person whose roll number start with 2 or who is having a roll number 3, it will give me all the details for that particular person. So roll number is a primary key for us. So basically an attribute which identifies all the records in a table uniquely. So basically this is a primary key. Now since these two tables have a relationship between them, so to establish that relationship there should be an attribute which is present in this particular table which should be present in another table. So basically here this attribute is roll number which is called as foreign key and it points to this. So what is foreign key? Foreign key is basically a key, or you can say collection of keys or collection of columns, which basically refers to the primary key in the another table. So basically this foreign key is referencing to the primary key in another table. They are having a relationship between them. Now the referential integrity comes into picture, which establishes some rules which should be there to maintain the data accuracy, to ensure that there is no data inconsistency and faster retrieval of data. Now in this particular table, first thing is insertion in the referencing table. Consider, so let me just give the name. It is a referenced table and this is a referencing table. So the first is insertion in the referencing table. Consider that I want to insert some details in the referencing table. Consider SID is 4, subject is biology and roll number is 4. So would it cause any violation, or what would happen? So see, now what is happening is we are inserting a particular row in the referencing table. Now what will happen is we have inserted this particular row in the referencing table, but do any student present in the student table whose roll number is 4? Is there any student who is having a roll number 4 and is present in the student table? There could be a possibility, there couldn't be a possibility, right? So this insertion may cause violation because we are not sure that roll number 4 exists in the student table or not, and somehow this subject table is taking a reference from the student table. So if this roll number 4 does not exist in the student table, it doesn't make any sense to add it in the subject table. So in the subject table we had added key a person who is having roll number 4 is having the subject name as bio and is having the subject ID as 04. But there isn't any student who is having a roll number 4 exist in the student table. So basically insertion may cause violation. Why I am saying may cause violation? Because consider now there could be a possibility that roll number 1 is taking 2 subjects, physics or chemistry. So I can insert data for roll number 1 twice or thrice or 4 or 5 times. So basically it's not important ki insertion will always cause a violation, but it may or may not cause in the case ki whenever there is a roll number which is present in the student table, and for that roll number I am making an entry in the referencing table, but it may cause violation whenever there is an insertion for an entry which is not present in the student table. Now coming to the second one, that is deletion in the referencing table. So let me just quickly draw. This is subject. So this is roll number, this is student name, and this is phone number. Now this is to subject ID, subject name, and then this is roll number. So I'll just quickly give the datas. 1 2 0 1 0 2, subject name physics, biology, name Rahul, Raj, Riti. Actually these three are the common name I use, and 0012, 0013, 0014. Now again this is the primary key, this is the foreign key, and it is taking reference from the primary key. Now what happens? What if there is a deletion in the referencing table? So basically this is the referencing table and this is the reference table. So consider today I have deleted the data for roll number 2. So I have deleted there is a roll number 2 which existed and has taken a subject biology. Would it cause any violation? Think. It won't. So why it won't cause any violation? Because see now, there are many roll numbers present in the student table. So there is roll number 1 who has taken a subject physics, roll number 2 who has taken a subject as bio. But what if roll number 2 doesn't want to take a subject bio? What if he or she gets promoted into next higher sections or higher classes and they don't want to take bio? So it will be deleted from the database of the referencing table. So does it cause any violation? No, right? Because see, after 10 you get an option ki bio or maths. So if I choose bio, why would I take maths? So I can delete this particular data from the database of referencing table. So basically it won't cause any violation whenever we are deleting anything from the referencing table, even if the data present in the reference table. So basically there might be a possibility that there is a student Raj with roll number 2 who is now not having bio as his additional subject or bio as his subject. Now he's opting for maths. Now the third and the last is the updation in the referencing table. So actually I'm drawing these tables because I want you guys to understand what is happening at the very depth. So let me just make it very quick. Student, subject, subject ID, subject name, roll number, student name, student phone number. So here 1 2 3, here also 1 2 0 1 0 2, subject physics, bio, name Rahul, Raj, Riti, and phone number 001 002 003, any random values. Now what happens ki whenever there is an updation in the referencing table, so basically this is the referencing table and this is the reference table. So whenever there is any update in the referencing table, what will happen? Think. So basically whenever there is an updation in the referencing table, now what happens ki consider that you want to update the student subject ID for that particular subject physics. Till then it's okay. If you want to update the subject name, what if roll number 1 now wants to take maths instead of physics? It's again okay. But what if you want to update the roll number? So basically roll number is acting as a foreign key which is taking a reference from the primary key which is present in the student table. So if you update the roll number, consider you update the roll number to 10, but there is no roll number with 10 which exists in this reference table. So does it make a sense? No. So basically what updation does is ki if whenever you are updating any of the values, which is any of the values apart from the foreign key, it may not cause violation, but whenever you are updating the values which is acting as a foreign key in the referencing table, it may cause violation because foreign key is referencing to the primary key of the reference table, and whenever we are making any update in the foreign key, it may cause violation because the same details may not exist in the student table. So roll number 10, if we have updated this roll number from 1 to 10, there is no such student with roll number 10 which exists in the student table. So how it would take a reference? There would be some data inconsistency. So basically here we won't find any roll number 10, and here we will find the details for roll number 10 who has or who hasn't taken any admission yet. So basically all these things happen whenever we are doing any kind of CRUD operations in the referencing table. So what is integrity constraint? Now consider that there is already an existing database, and consider there is a scenario where we are creating a database. So in this existing database, there would be some kind of update we would be doing in our day-to-day life, or some kind of insertions we would be doing in our day-to-day life. Now for that insertion and for that updating the values of some particular fields or some particular attributes, there are some set of rules which needs to be applied before doing any kind of insertion or any kind of update in the database. Now why this set of rules is needed, or why it is so much important? Now consider that there is a student table. Okay, so there is a student table in which we have fields like student ID, student name, and just a second. Okay, let me again draw it. So basically we have a table of student in which we have 2 columns and some fields. First one is student ID, second is student name, and third is student age. Now consider that there are already some existing data present in this table. Now consider that there is a new student who has taken admission in the school. Now I am inserting values for that particular student. So I have inserted the student ID 03, the name is Ram, and consider I have given the age ABC by mistake. So if ABC is inserted here now, this is kind of an invalid or incorrect data because student age can't be ABC, right? So there are some set of rules we apply at that particular time कि student age is a field which will only take integer values. Or consider that again I am entering a new field or a new record, and here I am giving student ID as 04, the name as Priyanka, and now here the age I am giving as -5. Again, no one age could be -5, right? So there are some invalid data which could be entered if we don't ensure that there is an integrity constraint or there are some set of rules which is applied. So basically integrity constraint come into picture whenever we are inserting any kind of data or whenever we are updating any kind of data in our database. They make sure that there are some set of rules which is enforced so that we don't mention or don't apply or don't insert any kind of incorrect data or invalid data, and data consistency is maintained all throughout the databases. So basically there are various type of integrity constraint. So the first one is domain integrity constraint, the second is entity, the third one is referential integrity, fourth is key, fifth is check, sixth is null, seventh is unique, and eighth is default. So basically there are various type of integrity constraints, and we would be knowing in brief about all these integrity constraints in next slide. So the first one is domain integrity constraint. Now what is domain integrity constraint? See, domain is something na ki consider that you have a table, theek hai? In that particular table there are some attributes which we usually call as columns and attributes in terms of DBMS. So there might be some columns or there might be some attributes, right? So for that particular attributes we give some domain that okay, if there is an attribute called as student name, it will only take character values. If there is an attribute called as student age, it will only take integer values. So basically what happens is ki consider we have a table, there are two columns, there is a name and there is a age. So basically in age we give that it will have integer values, in name we give that it will have character values. In age also sometimes we make sure that age shouldn't be 0 because no one is having an age as 0. Age shouldn't be negative values. So basically for these particular things we add a check constraint. So what this check constraint does is ki check constraint makes sure that a particular condition is fulfilled, only then the data is inserted in our table. So basically we'll put a check ki check if the age is greater than or equal to 0 and less than or equal to if there is some criteria present there. If not, you can put that check if the age is greater than or equal to 0, only then insert the data. So basically for this particular name we are inserting character values, for this particular field or attribute age we are inserting integer value. So basically domain constraint, it ensures that the validity and appropriateness of data values, that is valid data types, character or integer, ranges, check constraint ki it age is greater than or greater than 0, not equal to 0, ranges and formats for the column. So within a specific column or attribute of a table. So basically it ensures that the validity and appropriateness of data values within a specific column of a table or attribute. It basically ensures that the validity is there, the appropriateness is there, that the valid data types are going there, the valid ranges are going there, or the valid formats are going there. Now there is an example. Check for date column so that it contains only valid date values. So basically consider that there is a date field or date attribute which is present in the table, and in this date attribute someone writes ABC. Again, it makes no sense to give ABC in a date column. What does this mean? A date ABC, what does this mean? This means nothing, right? So there should be some checks which should be there for all the attributes. There should be some domain which should be given for all the attributes so that everything lies within that particular domain. There should be some range of values. There should be some domain of data type or some types of data types which should be there. Like there are many things which should be ensured in particular columns or the particular attributes of a table. So basically domain constraint make sure that these particular things are ensured. Now the second one is entity integrity constraint. So basically it ensures that each row or record in a table is uniquely identified by primary key. It also helps in preventing duplicate or null values in the primary key. So basically entity integrity constraint, it basically you can say that deals with the primary key. So what it makes sure is, it makes sure that each and every table have a primary key so that it can uniquely identify all the records in a table. Now what is primary key? Primary key is basically a attribute which is like unique plus not null. So any attribute which qualifies the unique constraint and the not null constraint is called as primary key. And entity integrity constraint makes sure that there is always a primary key which is present in the table. What primary key does is कि primary key help us to reduce all the duplicate values, maintain the data consistency throughout or within the table, and it also helps us to uniquely identify all the records in the table. So basically entity integrity constraint makes sure that there is always a primary key which is present in the table. So it ensures that each row or record in a table is uniquely identified by a primary key. Now the third one is referential integrity constraint. Now this constraint is basically dealing upon the foreign key. Now what is the foreign key concept? Foreign key is basically a key which references to the primary key of another table. Now what happens if there are two tables which are having a primary key and foreign key relationship? Consider that there are some insertions in one particular table and there is some deletion in one particular table. There shouldn't be any data inconsistency that should be there. So consider that there are two tables, one is having a primary key, another one is having a foreign key. So basically in that table which is having a foreign key, or the table which is the referencing table, if we add any value, right, if we add like we randomly insert any data in that particular table, so it will not reference to any particular student or any particular record which is present in the table A. So basically that particular data is an invalid data or an inconsistent data because it does not have any meaning. Let me just draw it and let you know. So basically there are two tables, table A and table B. These are having some attributes and these are also having some attributes. So basically there is a roll number, there is a course ID and course name, and basically this is a course table and this is a student table. So it is having student ID, roll number, student name. So basically roll number is acting as primary key here and roll number is acting as foreign key here, and foreign key is basically referencing to the primary key here. Now consider that there are roll number 1, 2 and 3. Here I am also giving roll number 1, 2 and 3. Now what if I add one more record in this particular table, roll number 4. Now this particular table, course table, is taking a reference from the student table, right? And now we have added a new particular record which is having a roll number 4, course ID as something and course name as something. So this particular roll number 4 does not exist in this student table now. So what it will reference to? Because consider that there are 3 people in a class. Now I have allotted a fourth person a particular course and a particular course ID, but the fourth person does not exist in the class. So does it make any sense? No, right? So basically there is data inconsistency which is there. So what referential integrity constraint does is it ensures that the values in a foreign key column match with the values corresponding to the primary key column in the another table. So it makes sure that roll number 1 is there, roll number 2 is there, and roll number 3 is there. So it basically makes sure that the foreign key values and the primary key values remain same or remains consistent. I guess this is the fourth one. So the fourth constraint is key constraint. It is the simplest constraint. So basically it ensures uniqueness for the primary key. So what does this key constraint does is it makes sure that there is at least one primary key which is existing in the table. So there could be like many keys, right? Consider that there is a table, student table. Now we are having student ID, student roll number and student phone number. Phone number is also something which can remain unique for every student. Student ID is also something which will remain unique for every student. Student roll number is also something which will remain unique for every student. So basically key constraint makes sure that there is at least one attribute or at least one key which is they're present in the table which will be serving as a primary key. So it ensures the uniqueness for the primary key. Now the fifth one is the check constraint. So what does this check constraint does? As I told in the previous slide, we put a check for the age ki age should always be greater than 0. If the age is greater than 0, only then go ahead and insert the data in the database. So check constraint basically checks for a condition that each row in a table must satisfy. If the condition is not met, the insertion or the update of the row is rejected. So consider that if we are giving age as -5, which is not passing this particular constraint, so basically this particular data is rejected and we can't insert this particular data in the database. Consider there is already existing data where age is 11. Now I update this particular data to -5. So the check constraint will check if the age is greater than 0. If not, it will not perform this update operation. Now the sixth constraint is the null constraint. It determines whether a column in a table can have null values or not. So basically this null constraint is given to some optional fields in the database. So consider that there is a student table. Now in that particular table we have a section called as student email. So there could be a possibility that many students don't have email, many students may have email. So that particular column is an optional column. So what happens ki if we give that particular null constraint, so what it will do is ki it will verify that if this particular column is an optional column or can accept the null value. See, if we give a null constraint, it will automatically fill null there. So basically if we left that particular attribute as empty, it will take that value as null. So basically it is like to make sure or to provide an additional check ki theek hai, there is a email attribute or there is a email column which many students may have email, many students may not have email. So you can go ahead and put null value in that particular attribute. There shouldn't be any case where we are inserting the values and we are not able to insert it because the email section we are leaving it as blank. Now I guess this one was the sixth. Okay, this one is the seventh. So unique constraint. Now unique constraint ensures that the value in a specified column or a combination of columns are unique across the table. This constraint prevents duplicate values from being inserted into specified columns, maintaining data consistency and integrity. So basically you have heard na ki primary key is attribute which is unique plus not null. So what does this unique means? Unique means na ki whenever we are inserting any values, it is unique. So consider that there is a table, student table. Every time I am taking this student table example. So basically there is a student ID, right? And this is acting as a primary key for the student table. So consider that for one person I have given the student ID as 01. For one person I have given the student ID as 02. Now for the next person I can't give the student ID as 01 because it will then not take into consideration this particular unique constraint. So whenever we give this unique constraint to any particular attribute or any particular column, it makes sure that if 01 value is inserted, it is not inserted next time. So there won't be any duplicate values. So basically this constraint prevents the duplicate values from being inserted into specified columns, maintaining data consistency and integrity. So 01 if inserted cannot be inserted next time. So basically unique means unique values will only be inserted. Every time new values would be inserted, none of the two values can be inserted which are same. Now the eighth constraint is default constraint. So what does this default constraint mean? As the name suggests, default. So consider if you are inserting values into your table, right? So if there is no value for a particular field or for a particular column, so there would be some default value which would be inserted for that particular field or that particular column. So basically it ensures a default value for a column which is used if no other value is provided. So consider that there is a field called as Aadhaar number. Okay. So for the students who are having Aadhaar number can go ahead and enter their Aadhaar number. But for the students who are not having their Aadhaar number, I want them to have no Aadhaar. So basically for the students who are having the Aadhaar number, they can go ahead and insert their Aadhaar number. But for the students who are not having their Aadhaar number, I want a default value to be inserted that they are having no Aadhaar. So basically default values comes into picture in this case. What will happen that student A will try to insert his or her data. Now whenever the Aadhaar field needs to be inserted or the Aadhaar data needs to be inserted, student will leave it as blank because they don't have any Aadhaar, and a default value called as no Aadhaar would be inserted in that particular case. So what is super key? So before knowing what is super key, I would like to revise some concepts of primary key and candidate key. So consider that there is a table of student. Okay. So basically consider that there is a student schema. Now in this particular schema there would be some attributes or columns. So consider that there are attributes such as student ID, student name, student phone number, and student Aadhaar card. Okay, so basically this is the student schema. Now in this particular student schema, we need to know what is the candidate key and the primary key. Now what is candidate key? Candidate key is basically attribute or set of attributes which can uniquely identify records in a table. So any attribute which could help us to uniquely identify the records in a table is called as candidate key. So basically for the candidate key, let's have a look through on the schema one by one. So the first attribute in the schema is student ID. Now does student ID qualifies to be a candidate key? Yes, it qualifies because student ID is something which can uniquely identify records in a table. If I give a query or if I make a query based on student ID, give me the details of that particular student whose student ID is 001. So it will give me the details of that particular student whose student ID is 001, and none of the students would be having the same student ID. So it is kind of uniquely identifying records in the table. So student ID is a perfect option for the candidate key. So what I'll do is I'll mention it in the candidate key set. Now second is the student name. So there could be a possibility now that two people or two students are having the same name. Consider that there are two students in the class and they both are having the name as Abhishek. So basically if they both are having the name as Abhishek, there is a possibility that if I make a query based on student name, I could get some details of another Abhishek, but I want the details of Abhishek whose student ID is 002, but there is a possibility I can get details of Abhishek whose student ID is 003. So because of this case, we discard this particular student name from being a candidate key. Now the third one is student phone number. Again, phone number is also something which can uniquely identify records in the table, like if I give the phone number of a particular student. So it may give me all the details of that particular student, and phone number is something which can't be same for every person, and we can give this as a possible option for candidate key. I'm not talking about primary key, but it can be a possible option for candidate key. So student phone number is also something which can be a possible option for the candidate key. Now the next one is student Aadhaar. Again, Aadhaar is something which is unique for every student, so we can give it as a possible option for our candidate key. So student Aadhaar is also in the candidate key set. Now the next key is the primary key. So basically there are two differences between candidate key and primary key. So basically candidate key is something which uniquely identifies the records in the table. But in case of primary key is a key which comes from a candidate key or is a key which is derived from the possible options of candidate key. Also, primary key is something which should always be unique and which shouldn't be null. So basically if these two constraints, unique and not null, is present in a particular column or in a particular attribute, it qualifies to be a primary key. So basically there are three candidate keys here we have seen. Now among these, which can be a primary key? So student ID, again whenever any student takes admission, they have the student ID or the student registration number generated. So it will be unique for every student, and it is obvious that every student who is taking an admission is having a student ID. So student ID is always unique, plus student ID is never null. So student ID can be a primary key. Now coming to student phone number. Now consider that there are many students who don't have phone number or who can't give their phone number, like we are going into the 90s era, but there could be a possibility that students can't give their phone number, or there could be a possibility that there are siblings in a class who are having the same same father, and due to the same father they would be having the same phone number. So again, student phone number is something which can at times remain unique but at times can't remain unique. So student phone number is something right now we won't be giving a possible option or considering a possible option for primary key. So for now I am discarding student phone number from the primary key. Now again, the third attribute is student Aadhaar. Student Aadhaar is also something like many students may not have their Aadhaar card number generated or Aadhaar card made. So there could be a possibility that some people might have Aadhaar card section as null. So basically, as primary key is something which is unique plus not null, so Aadhaar card is also something right now we can't consider in the primary key. So from these particular discussions we have come that student ID is something which qualifies for a primary key. Candidate key, a key which uniquely identifies all the records in a table. Primary key, a key which uniquely identifies all the record in a table but it is unique plus not null. Now coming to the main topic, that is super key. So basically what happens now, in super key is basically a set of attributes which uniquely identify records in a table. Now why super key came into picture? So consider that there is a candidate key, okay. So there is a candidate key SID, okay. For now let's consider only one key. So in candidate key, student ID is there. Now super key is basically a superset of candidate key. Superset means super key, if there is any combination of super key or any composite keys which are present, there would always be a candidate key. So whenever we are adding more attributes to the candidate key, it becomes a super key. So you can understand in this way primary key is something which is derived from the candidate key, like from all the possible options we select the best option to be the primary key, and in super key we consider all the attributes of the candidate key or some of the attributes of candidate key, plus there are some extra attributes which is also added, but candidate key is something which is always must in a super key. So if we are making any super key or combination of super keys or composite keys, there should always be one candidate key. So what happens in super keys, consider that right now this is also called as super key. So what is this is called as minimal super key. Since there is only one attribute, we can call it as minimal super key. So what is minimal super key? Minimal super key is basically called as candidate key. So whenever there is minimal or there is minimum attributes which are present and the attribute reflects that of candidate key, it is called as minimal super key. Now super key is something which is having a candidate key, and then we can have some more attributes from our particular schema or from our particular table. So basically candidate key is having all possible attributes which can uniquely identify records in a table. Super key is something which is taking into consideration the candidate key. Apart from candidate key, it is also taking some extra attributes into picture to make that particular combination. So what will happen here is candidate key is student ID. Now super key, minimal super key is student ID. But if I want to make super key, I can also make a combination of student ID and student name. So basically this can act as a super key for me. So what it will do is give me the details of a person whose student ID is 001 and whose student name is Riti. So it will fetch me all the records, all the details of that particular student whose student ID is 001 and student name is Riti. So basically it is also a set of attributes which is helping us to uniquely identify records in a table. But super key is something there can be much more attributes which is like not needed really to identify records in a table. But super key is something which will always have at least one candidate key. So basically it is a set of one or more attributes that can uniquely identify a tuple in a relation. Superset of any candidate key is called a super key. A super key becomes a candidate key if it is minimal, that is no proper subset of it can uniquely identify a tuple. Now let's see one small example. Won't extend the video much. So let's have a look at small example. It's kind of a small numerical, you can say, for now. So let me just rub it very quickly. Till then, again I am reiterating. Candidate key is the set of attributes which uniquely identify records in a table. There could be one or more attributes. From all those attributes, we choose the best option, and that is a primary key which is unique plus not null. And super key is a combination of set of attributes which have at least one candidate key. So these were the meanings about all these. Now consider that there is a employee schema. Okay. So there are many employees, E1, E2, E3 till En. Now consider that we have given that in this particular schema, E1 is the candidate key. So I need to know that how many super key can be possible, how many combinations of super key can be possible. So basically we have an employee schema. In that particular employee schema, there are n number of employees. For now I am not defining the number n. There could be 8, there could be 18, there could be 800, there could be much more. So we are taking n into consideration. So there are n number of employees in a company or whatsoever you think. So there are n number of employees. For that n number of employees, there is one candidate key, that is E1. Now since we have one candidate key, we need to find out how many super keys are possible, how many combinations of super key are possible. Now let's start. So basically you guys might have read about probability. So what will happen? There are two possibility of E1. Either E1 can be a part of combination, either E1 can't be a part of combination. Either E2 can be a part of combination, either E2 can't be. Either E3 can be or can't be. Either En can be or can't be. So right now E1 is the candidate key. Now whenever we are making a super key from that, so E1 is a candidate key. So E1 E2 can be a possible combination. E1 E3 can be a possible combination. E1 En can be a possible combination. E1 needs to be there every time, because as I told that super key is something which is having at least one candidate key. So at least one candidate key needs to be there. So there can be multiple combinations from this, right? And every E1, E2, E3 can have two types of they can have two combinations. Either they can be there or they can't be there. So E2 can be there or E2 can't be there. So there are always two possibilities for that. So if we calculate it from here, 2 till n, so it can be called as 2 to the power n. But again, E1 is something which is remaining, like it's evident in all the combinations, right? So E1 is also there, E1 is also there, E1 is also there. If I'm doing E1, E6, E1 is always there. So E1 is something which is always there. So there is no possibility that E1 will never be there. There is only possibility that E1 will always be there. So what we do is after that, the final remains is 2 to the power n minus 1 can be the super keys. How it is 2 to the power n minus 1? So basically every E1, E2, E3, E4 till En has a possibility that it can be there, it can't be there, it can be there, it can't be there. But one of them is the candidate key. So when one of them is the candidate key, the possibility of not being there is vanished. So there is only possibility of being there. So we do it 2 to the power n and minus 2, that was 2 to the power n minus 1. So basically 2 to the power n refers to all of the possible combinations, and eliminating one combination from this is 2 to the power n minus 1. So now the first question comes into mind is, what is ER model and why we are learning ER model? So let me just explain you from a very small or basic example. Consider that you are a developer. Now you have to make an API, okay? So you have to make all the API, all the calls which are present in that particular API, all the database calls and everything. So basically there could be an API in which there are some clients which are being called, some database queries which are being done, some database calls which are done. So basically an API have many calls, okay? Now your team leads come to you and explains you, okay, this API is doing this, and finally giving the result. So you are having a request body and you are getting a response body. Now what happens is team lead comes and tell you about all these. At that particular moment of time, you remembered okay, this particular thing is being called, then there are some clients being called, then there are some database queries which are being happen or database calls which are being happen, and then we are getting the final response. Now consider after 3 days you forgot about one client, or you forgot about one DB call, or consider that there are some changes which is happening and you are not still pretty sure that what all things you were doing at the very first, and now you need to do some changes as well. So what thing you can do at that particular time? So at that particular time, what you can do is कि when your team lead is explaining you, just jot it down in pointers and make a low level design of that particular API. So what you will do is कि you will make a design of that particular API कि okay, the API is getting some request, it is validating some request, and then it is calling some clients from there, it is fetching some data, then it is calling the database, and after all these we are building the final response. So basically LLD diagram at that particular point would save a lot of time of yours, because you would be pretty sure about ki what all things are happening. And also you can ask your team lead ki please review my LLD diagram and is my understanding about the API correct, or is there any changes needed, or whenever your team lead suggests some changes, you can just go ahead and make the changes in the LLD diagram. So you can see na, diagram or design is somehow like making things so much easy and somehow also saving our time, right? So in the same way, like a very basic example of Maggie. So consider that you are making Maggie for the first time. Now you need some instructions that how to make a Maggie. So whenever you see that Maggie packet, you see in the background there is like in the back there is some pictures which is given, and there are some instructions which is provided. Okay, then tear the plastic and then boil the water and then put the masala and then the noodles and stir it for 2 minutes. So there are some instructions which is being provided, there are some images which is being provided. You just follow that and you are like good to go to make a Maggie. Okay, so basically what happens is whenever you are following any design or any diagrams, it makes task very much easy for you to implement ultimately what you want to do at the very first point. So in the entity relationship model, what happens is ki ER model basically help us in designing a flow chart or the diagrams or everything which is needed for our like entities, relationship, and what all things are being happened. Now consider, let's take an example of Instagram. So in Instagram, there are many features present there, adding a story, uploading a post, and much more things. So consider that today I told you that implement the feature of uploading the post in Instagram. So there are many steps which are being followed. First, you select the picture, click on the post plus icon, then you select the picture, and then you go ahead and see if you want to apply some filters and much more things. So there are many steps which are being involved for uploading a photo in Instagram. So all these steps, if documented in a very great way or in a very good way, it is diagrammed and designed, it would be very easy for you to understand the overall API of uploading the post, and also it would be very helpful for you to implement that particular API. So in the same way, ER models makes our task easy. So now what is ER model? ER model basically stands for Entity Relationship Model. Now as the definition suggests, entity relationship. What is entity? Any object or anything which is having some physical existence is called as entity. For example, consider person. Person is an entity. Example, student. Student is an entity. So basically anything or any object which has a physical existence is called as entity. Now what is attributes? So basically the characteristics of that particular entity is called as attributes. So you might have heard this term schema in the last set of videos. So what is schema? Consider that I need to give student schema. So what I'll mention is I'll mention the entity name, and then I'll provide all the attributes such as student ID, student name, student roll number. So in the same way, it is this is a schema of student. This is a student schema. So in this particular student schema, student is the entity. Student ID, student name, student roll number is the attributes. And now coming to the third thing, that is relationship. Now I have given many examples where I have taken two tables. First one is student table and second one is a course table, which was having a primary key, foreign key relationship between them. So in that particular videos, I also told that student is having some relationship with the course. So basically student and course have a relationship. Student is taking this particular course for that particular class or that particular standard and that particular roll number. So basically a student is taking this particular course. So basically there was a relationship between student and course table, that student is taking or opting or studying that particular course. So in relationship what happens is we define it in a diagrammatic way. So what will happen is there is a student database, now there is a course database, and now what is the relationship between student and courses? Student studies course. So basically we give student in rectangular format and study like the relationship in the diamond format. So what happens is student is now studying a course. So basically entity relationship model is we define the relationships between the entity that is studies, and entities are present here, and attributes are basically the characteristics of entities. So attribute can be student ID, which we give in ellipse, then student name, and much more things. So basically this is the basic funda of ER model. So let me just clear the screen and let's go one by one. Okay, so so introduction to AR model. Entity, things or objects is called as entity. Example, person. Now attributes, properties of entities or characteristics of entities called as attributes, such as names, age, student ID, and much more things. Relationship is association among the entities, that is works for or studies or like much more things. Okay? Now the entity relationship model stands as a prevalent conceptual modeling approach within the realm of the database design. Its primary role is to offer a visual representation of a database architecture by illustrating the entities, their respective attributes, and the interconnections between them. So what is happening is it is basically a virtual representation of a database. So the database is very huge. Now in that particular database there are some tables which is having some relationships in between them. So what will happen, we'll just design that particular database. So consider that there is a student database. In that particular database there are many tables, student table, course table, then fee details, and much more things. Now it will define that what are the relationship between these particular entities. In the process of database design, the ER model holds significant importance, aiding in the development of an efficient and systematically structured database schema. So as I told, if I am having an LLD diagram, I can design, I can implement the API very quickly. If someone who is very new to that particular API and don't know anything about that API, if I give him the LLD diagram, him or her, they can implement the API very easily. So basically LLD diagram or visual represent or designing is something, if we hand over to anyone, it will make the process very easy. The designing of the database, when it's done, we can go ahead and implement the database, we can go ahead and know about the database, what all tables are there, and much more things. So basically it is somehow making our task very easy. Now in the ER model, as I told, that ER model starts for entity relationship model. Now there is entity, there is attribute, and there is relationship. Now there are types of entities as well, strong entity and weak entity we will be knowing in the coming videos. Now in the attributes also there are many attributes like simple, composite, single valued, multi-valued, stored, derived, composite. So basically about all these attributes we would be again knowing in depth in the next set of videos. I'm just letting you know that there are entities also divided in some subtypes, attributes is also divided into subtypes, and relationship is also divided into some subtypes. Relationship, or also called as cardinality, is also there: one to one, many to one to many, many to one, and many to many. Now these are the symbols which is basically used in the ER model. So as I told, consider that there are two entities. So firstly I'll give the schema. So I'm giving the schema for student and course. Now student schema has student ID, student name, and course schema has course ID, course name. So what is this? This is basically entity. So what I'll do is according to the symbol, entity is represented by rectangle, so I'll give the name student. Now again course is also one entity, so I'll give it in rectangle shape, course. And now attributes are represented in ellipse, so attributes are nothing but the characteristic, so we'll give the attributes student ID, student name, and then the attributes for this: course ID, course name, and now at the very last we give the relationship among them. So from the diamond it is given, and the relationship is study. So basically in this way we design the ER model. This is a very basic ER model design. We would be knowing in much more depth about some complex database designs as well, but this is just a small example that how we are designing everything from entity to attributes to relationship. So basically this is the student schema, this is the course schema, and whenever we have this particular schema we can go ahead and design our entity relationship model or design the visual representation of that particular model. So there are much more things, like line is like attribute to entity relationship, then double ellipse is multi-valued attributes, and double rectangle is weak entity. As I told here that there are many subtypes of attributes and entities, so we would be looking about that in the next set of videos. Now this is a normal example of ER model as I explained earlier as well. So there is an entity called as professor, there is an entity with the name student. Now there is a relationship between the professor and the student, that is teaches. So basically relationship is teaches. Now student may have some characteristics or may have some attributes, so that attributes is represented using ellipse, and the attributes are ID, name and subject. So these are the attributes, this is the entity, this is the entity, and this is the relationship. So basically in the last slide I also explained about this particular example of student and course. In a similar way there is example of student and professor. So this was all about ER model in this particular video. Let me just revise from the very basics. So ER model stands for entity relationship model. Entity relationship model helps us to give a visual representation of our database, so that designing of database, when it becomes easy, the implementation of database also becomes easy. So ER model is entity relationship model. Entity is basically any object or anything which has a physical existence. Relationship is a relationship between the entities, and attributes is basically the characteristics of the entities, like student ID, student name for a student table, and course ID, course name for a course table. Now again, entity and relationship have some subtypes, also attributes also have some subtypes. So about all those types and about all the types of entity and relationship we would be having a look on next video. Basically it is providing a visual diagram to us which would help us to implement the database very easily and very effectively. So what is an entity? An entity is something from the real world, like a person, place, event or idea that has some physical existence. Now each entity has specific features or traits that can describe it. Now consider that I am taking an example of person. So person is an entity because it is like a real world object which has some physical existence. Now person may have some characteristics, which could be person name, person age, person address, and much more things, right? So all these characteristics are called as attributes of a person. So that is told here that each entity has some specific features or traits that describes it. So basically person name can describe it, person age can describe that the person is having this age, the person address can describe that the person lives here. So there are some special features or there are some traits which particularly define an entity, that is called its characteristics or attributes. Now there are two types of entities. First one is a strong entity and second one is a weak entity. So let's have a look on that. So types of entity. First is the strong entity, second one is the weak entity. Here I have given an example of person entity and dependent entity. So what is strong entity? From the word you can see now, कि strong entity is something which is strong, right? So a strong entity is basically an entity which does not depend on any dependent or does not have any dependence on other entities. So basically it can exist alone. So let's take an example. Consider that we have taken an example of person entity here. So why person entity is called a strong entity? So person entity itself can define all the attributes of the person, like the name, the age and much more things. So it's not dependent on other entities ki, okay, here you get the details of, okay, Raj is a person who is having an age as 20 and the phone number is this, the Aadhaar card number is this, and much more things you can know here. So it is independent. It does not depends on other tables or other entities to gather information, or like it can independently exist. So basically a strong entity is something which can independently exist. It does not depends on other. Second thing is strong entity is an entity which is having a primary key. Now coming to the weak entity. Now what is weak entity? Now consider that there is a person table, right? And in the weak entity I have given the dependent table. So basically person has some dependents. Consider that there is a person who has some dependents like his mother, his father, his children, and much more things. Now if the person table is not there, would you be able to know that, okay, there is a section called as mother and the mother name is given, but whose mother is this? So if the person table is not there, you won't be able to know that whose mother, whose particular mother or whose particular person mother is this. So basically dependent table is something which is kind of dependent on the person table, because person table is somehow like the dependent table is somehow gathering information from the person table, and this particular table is solely dependent on this table, that the parent is this, the wife is this, or the children is this. Let's not confuse you. Let's go ahead and have a look on the definition first, and then again we will learn from an example. So basically types of entity. Strong entity. A strong entity is an entity that has its unique identifier, that is primary key, and it's not dependent on any other entity for its existence within the database. Strong entities stand alone and have their own set of attributes. Example, person. Now in the weak entity, a weak entity is an entity that does not have a primary key of its own. It relies on a related strong entity known as owner entity for its identity. The weak entity existence is defined by being related to the owner entity. Now example is dependent. Now let's understand the strong entity and weak entity in detail. So consider that there are two tables. So first is the student table and second is the course table student has taken. So it has course ID, course name, it has student ID, student name, and student age. It also has the student ID. So do you remember in last set of videos we learned more about primary key and foreign key relationship. So basically there are two tables. One is a student table, one is a course table. Basically student ID in the course table is a foreign key which is taking reference from the primary key in the student table. Now what happens, ki consider that there are two entries. First one is Riti, second one is Ram, and the age is 20, 21, and the course ID here is 01, 02, course name is physics, course name is maths, the student ID is 1 and 2. Now from these two tables it's evident a person or a student whose roll number is 1 has taken the course name as physics and course ID is 01. A student whose ID is 2 has taken a course name maths and is having a course ID as 2. So from where do we get the details ki who is roll number 1 and who is roll number 2? From this particular student table. So student is an example of strong entity and course is an example of weak entity. Let's understand how. So basically student table can exist independently. It doesn't need to gather information from some another table ki okay, for roll number 1 what is the student name or what is the student age. It can exist on itself. And also the second thing is ki this particular table is having a primary key. This is a foreign key. So basically there are two things which are needed for an entity to be a strong entity. First one, that the entity should exist alone. If there are any hindrance in another tables, it shouldn't affect this particular table. So it can exist alone. The second thing is the table always should have a primary key. So all these two things are verified in this particular student table. So student is a strong entity. Now coming to the course table. So basically course is somehow having a foreign key primary key relationship with student. So it is called as a weak entity. Because again I told na ki there is one student whose roll number is 1 and has taken course name as physics and course ID is 01. But what if this table is not here? So would you be able to find ki okay, roll number 1, who is the person who is roll number 1, or who is the person whose student ID is 1? Would you be able to find ki 2, who is the student who is having the student ID as 2? So this table can't exist independently, and it also doesn't have any primary key. It just have a foreign key which is taking a reference from the student table where student ID is acting as a primary key. So basically it can't exist alone and it doesn't have a primary key. So it is called as weak entity. Basically strong entity is represented by 1 rectangle and weak entity is represented by 2 rectangle. And whenever there is a relationship between a strong entity, that is student, and a weak entity, that is course, the relationship among them is defined via 2 diamonds. Studies. So this is student, which is a strong entity, so a single rectangle. Course, which is a weak entity, so 2 rectangles. So basically this is the way we represent entity relationship between strong and weak entities. Attributes in DBMS. Now what is attributes? So I told that entity is something which is basically having a physical existence. So basically whenever I am taking an entity example, consider person. So basically person is an entity. Now person may have some characteristics such as person name, person age, person address, and much more things. So these are the characteristics of person which we generally called as attributes. So basically these are called as attributes. Now in attributes also there are some types of attribute about which we would be learning in this particular video. So types of attribute. So the very first attribute is a simple attribute. As the name suggests, something which is very simple, or like simple attribute is something which can't be further divided. So a simple attribute is an atomic and cannot be divided any further. Example, first name. So consider that there is a student, right? So student would be having name as an attribute, and name can further be divided as first name, middle name, and last name. So basically these all three, first name, middle name, and last name, these are the attributes which are called as simple attributes because they can't be divided further. Name can be divided further. Name attribute can have more attributes such as first name, last name, middle name, in such a way like address attribute can have street, city, pin code, and much more things. So in the same way, name attribute can have further attributes, but the further attributes such as first name, middle name, last name cannot be further divided. Also there is one more attribute you can take it, an example is age. So age is also an attribute. I have given the student age is 18. Now what kind of further modifications or further division it needs? It needs nothing, right? So basically simple attributes are the atomic attributes which cannot be divided further. So simple attribute is an attribute which cannot be divided further, and for your information, attribute we represent it using eclipse. So we can say first name is a simple attribute. Now coming to the another attribute, that is composite attribute. So going to the same example, so there is a student, so there would be attributes such as name, attributes such as address. So name is again an attribute which can be further divided. So it could be first name, last name, middle name. Address can also be further divided into street, city, pin code. So basically these attributes which can be further divided are called as composite attributes. So composite attributes is made up of several smaller part of attributes where each part represents a piece of a whole attribute. In simpler terms, it is composed of attributes which can be divided further. So name is an attribute which can be divided further. Address is an attribute which can be divided further. So these attributes are called as composite attribute. Example name, which could be first name, last name or middle name. Now the third attribute is single value attribute. From the name itself, it's clear that these values or these attributes have a single value. So basically a single value attribute is an attribute that holds a single value for each entity. So consider that again there is an attribute age, there is an attribute student ID, or there is an attribute consider course ID. So all these attributes would only have a single value. So age is considered 18, student ID is 1, 2, 2, 3 or CID is 0, 1, 2. So these attributes can't be divided further and they have single value. So basically they don't have multiple values, they have only single value. Consider that student phone number. So there could be multiple values for phone number. Consider you are giving your father phone number, your mother phone number or your local guardian phone number. So phone number is something which can have multiple values, but age is something you can't say na ki a student is 18 and 21 at the same time, right? So age is something which is a single attribute. Now again student ID is something which is unique for every student, so you can't say ki my student ID is 1223 and 1224. So it's not possible, right? So it would always have a single value. So basically a single value attribute is an attribute that holds a single value for each entity. Example age. Now next attribute is multi-value attribute. As from the single attribute it's clear, single attribute is something which is having a single value. Now multi-valued attribute is something which is having multiple values or can have multiple values. So a multi-valued attribute in a database is an attribute that can hold multiple values for a single entity. Example address. So you have filled so many forms, right? So in so many forms you can see, or in the diary itself, whenever we take admission into any school, in the diary itself you can see there is two fields for address. One is permanent address, second is residential address. So basically address is an attribute which can have multiple values. Consider that permanent address and residential address. So basically attribute is something which can have, this address attribute is something which can have multiple values. So basically an attribute which can hold multiple values is called as multi-valued, and an attribute which needs only single value or can hold only single value is called as single-valued. So basically in multi-value attribute we represent the attribute using two circles. So address can be represented in this way. Now next attribute is stored attribute. So attribute that is stored as a part of database record. So in stored attribute, it is an attribute which can be stored. Consider date of birth. So date of birth is an attribute which can be stored, right? So date of birth is something which you can store and you can give to the system. Now coming to the next attribute, that is derived attribute. So a derived attribute is derived from other attributes within the database. Like age is derived from date of birth. So right now I told you about stored attributes. So date of birth was something which was a stored attribute. So we stored the value of this attribute in the database. So it is called a stored attribute. Now from this date of birth, consider that there are many employees in my company and they have given their date of birth, and I want to know the age of that employees. So from the date of birth itself we can know the age of that particular person. So basically age is a derived attribute taking reference from date of birth. So derived attribute is something we represent through dotted ellipse. So age is something which is being derived from date of birth. Consider in case of salary also. So in salary there are multiple parts. So first is base, second is the stocks, third is the bonus. So using all these attributes we derive the total salary. Just a second. So we derive the total compensation, that is TC. So basically TC is something which is getting derived from other components such as base, stocks and joining bonus. So basically total compensation is something which is a derived attribute, and it is being derived from base, joining bonus and much more multiple components. So we can say that as a stored attribute. So the next attribute is complex attribute. So complex attribute is an attribute that is made up of multiple smaller attributes. So whenever we made attributes from smaller attributes, it is called as complex attribute. Consider an example of address. So basically in address, it is a composite attribute because it can have attributes such as street, pin code and city. And at the same time, address is also acting as a multi-valued attribute because address can be of can hold two values. First one is permanent address and second is residential address. So basically residential and permanent are the two values it can hold, and it is a complex attribute because it is a composite attribute because it can be further divided into simpler attributes. So there is one more attribute, that is a key attribute. So basically key attribute is something related to uniquely identifying records in a table. So basically a key attribute is an attribute which helps to uniquely identify records in a table, and it's always unique. So key attribute is something which is always unique. So consider that in this particular case of student, let me just write it here. So student, there can be multiple attributes: student name, student age, student ID. So again, student name is something like two people can have the same name. Student age is also something like two people can have the same age. But student ID is something which is always unique. So it acts as a key attribute, and whenever there is a key attribute, because it is acting like unique, it is acting like uniquely identifying all the records in a table, we represent the key attributes using a small line inside the ellipse. So basically, let me just re-revise about all the attribute symbols. Okay, so basically attribute is represented using ellipse. Now there is a derived attribute which is represented using dotted ellipse. Now there is a key attribute which is represented using ellipse, and inside there is a line, and then there is a multi-valued attribute which is represented using double ellipse. So this is a simple attribute, this is a derived, this is a key, and this is a multi-valued. Now let's see at the term what is the types of relationship. So basically like types of attributes and types of entity. In types of entity we got to know more about strong entity and weak entity. In the same way here also strong relationship and weak relationship exist. So let's see that what is strong relationship and what is weak relationship. So first we'll start with the strong relationship. Now what is a strong relationship? A strong relationship exists when two entities are highly dependent on each other and one entity cannot exist without the other. So basically a strong relationship is established between two persons when they are inseparable, right? So in simpler terms, that when two people are inseparable, they have a strong relationship, and when they can be separated, somehow they have a relation but they can be separated, is called as weak relationship. So in this case, strong relationship is when an entity is highly dependent on another entity and cannot exist without another entity, that is called a strong relationship. Now here I have taken an example of customer and order. So okay, so basically there is a customer and there is an order. Now every customer places some order, right? So every order is placed by a customer. Now in customer there would be some attributes such as customer ID, customer name, customer address and much more, right? And order also may have some attributes such as order description, order ID and much more. Okay, so what happens is ki for every customer there is a order, right? So for every customer ID there is a order which exists in this particular table. Now what will happen when I delete this customer table? So there would be some customer IDs present, but these customer IDs does not exist because the table does not exist. So in the very starting of the video, I explained about primary key, foreign key relationship. So basically in this customer table, the attribute CID is acting as a primary key, and in this order table, CID is also present and it is acting as a foreign key which is taking a reference from the primary key of another table, that is the customer table. So they have a relationship established between them. Now what if I delete this customer table? So all the customer details would be gone, all the customer IDs would be gone. Now here from this customer ID, this table is taking reference from this particular table, but since this customer ID is deleted, or this customer table which is having a customer ID is deleted, it won't be able to take a reference. So they both are dependent on each other. So basically the one which is having a primary key is called as parent, and the one which is having a foreign key which is taking a reference from its parent is called as child. So basically here the child has a foreign key, here the parent has a primary key. The child is having a foreign key which depends on the primary key of parent. So if the parent is deleted, the primary key of parent is deleted, then the child won't be able to take any reference from the parent, and it will result in the referential integrity rules breaking. I made a video on the same, that how the rules are breaking in referential integrity and how we can achieve that referential integrity is also there. So referential integrity rule would be broken, so in this way a relationship couldn't be established. So this is called a strong relationship. Strong relationship means something which is inseparable. So when two entities depend on each other for their existence is called a strong relationship. Whenever there is anything which happens to one table, it affects the other table. Now the second is the weak relationship. Again I told ki strong relationship is something where things are inseparable, it couldn't be separated. But in weak relationship we can try to separate them, it won't affect much. Okay, so a weak relationship on another hand exists when two entities are related but one entity can exist without the other. So whenever there is a use case when one entity can exist without the another entity, that is a weak relationship. Let's understand from an example. So here I have taken two entities. The first entity is order, the second entity is order item. Now order is having a order ID as primary key. Order item is having a order ID as foreign key which is taking reference from the order table. Now order item also have a order item ID which is a primary key in this order item. So basically consider that this is a order item table and this is the order table. Now order table has order ID, order name, order description, and order item is having order item ID, OIID. So just make it OIID, order item ID. Order ID which is basically taking a reference from this table which is called as foreign key in this table, and consider order item name. Okay, so now this particular order item ID is acting as a primary key here. So basically order ID is a primary key in the order table which is a parent table, and order item ID has order item ID as the primary key. Sorry for confusing with the words. So order ID is a primary key in order table, and order item ID is the primary key in order item table. So basically this is also having a primary key, this is also having a primary key. Now there could be chances na ki you place a order and order item details and everything is attached to that particular order, but order item is something which can exist independently as well. Like there might be some products in backlog, or there might be some products which is not yet bought by you, so there are order items. So basically order item is something which can exist independently even if there is no order table. So a weak relationship is a relationship where the two entities are related but one entity can exist without the other. So basically order item can exist without order, but yeah, at the time of making order, whenever a customer places the order item are attached to that particular order, but before placing of that order, the order item can exist independently. So this is weak relationship. Strong relationship, when things are binded, can't be separated. Weak relationship, things can be separated but they somehow have a relationship between them. Now what is degree in DBMS? So a degree in DBMS refers to the number of attributes or columns that a relation or table has. So basically the number of attributes your entity is having is called as degree. It's degree. So consider that there is a customer table. Now customer may have some attributes, customer ID, customer name, customer Aadhaar details. So the degree is 3. So basically the number of attributes or the number of columns in a relation or in a table is called as degree. Now here is the type of degree. So degree is 1. The name we told it as is a unary degree, and a relationship with a single attribute is called as having a unary degree or degree 1. Now degree 2 is called as binary degree, and a relationship with 2 attributes is called as binary degree. Now degree with 3 is called as ternary degree, and a relationship with 3 attributes is called as ternary degree. A degree of n is n array degree, and a relationship with more than 3 attributes is n degree, where n is greater than 3. So consider that there are 2 entities. Let's make a schema of person and customer. Now this person schema may have some characteristics such as person name, person age, and this customer may have customer ID, customer name, customer address. Now to calculate the degree for this particular entity and this particular entity, what we do is we calculate the number of attributes. So here it is 1, 2. So basically it is 2, so it belongs to binary degree. Now in customer table there is customer ID, customer name, customer address. So 1, 2, 3. So basically the degree is 3 and it is called as ternary degree. So in this way we calculate the degree. Now null value. So in DBMS, a null value can occur for various reasons. Not needed information. Sometimes some details are asked, but they don't apply to everyone. For instance, asking for a spouse name for someone who isn't married. So basically, what is null value in DBMS? So you might have seen many places, or whenever we create some tables, we give that this can be null or this can't be null. So some of the attributes we give that this can be null or this is optional. So consider that student is filling Aadhaar card details or PAN card details. It's not possible that each and every student would be having a PAN card. So we can't make that particular column a mandatory, or we can't make that particular column not null, because null values can exist. In the same way, there is some not needed information. So basically consider that you are being asked your spouse name, but you aren't married, you are a single person, so you won't fill any data. So that particular data would be filled with null value. Now here are the instances that why null value basically is used, or what could be the simple use cases why the null value exists. So the first use case is not needed information. So whenever there is a not needed information, we can use the null value. Now second is don't know the answer. Every now or then we are asked a question, but we don't know an answer yet. So you may have dealt this in day-to-day life, that you are asked a question and you simply blank out because you don't know the answer. So in that particular case also null value can exist. So there are some hypothetical questions which are being asked. Do you think a bird can fly, walk, cry, eat at the same time? So again, it's a very lame example, but again there are some questions about which you don't know the answer, so you can put it as null. So basically null value can come in that place as well. So the third thing is forgot to fill in. Like when you are filling out a form and you accidentally miss putting in some important information. So what happens now, whenever we are filling a form, there are some fields marked with asterisk, that these particular fields are required field, but there are some fields which are not marked with that. So what values would be filled for that particular field? So their null value can exist. So sometimes you are being asked that what previous internships you did, but you didn't did any internship. So in that case you make that value or make that field null, like you leave that. So null is automatically put into that. So basically on the types of degree, or on the basis of cardinality, there are 4 relationships. So what are the relationships? First one is 1 to 1, second one is 1 to many, third is many to 1, and fourth is many to many. So in this particular video, we would be knowing in much more detail about one-to-one relationship, and then there would be a dedicated videos about all those relationships. So basically starting from one-to-one relationship. So before starting, I would like to re-revise some older concepts of yours. So why are we studying ER model, or why are we studying relational model, and how is it all related to SQL and much more things. So basically what happens now, from the very beginning we read about database schema. So there was a database schema in which we basically used to give the entity name, consider person, and then we used to provide all the characteristics, or you can say attributes, such as person ID, person name, person age. In the same way we do for other entities as well. Now what happened ki from the database schema we designed an ER model. As to design an ER model, we need some data like what is the entity name, now what are the attributes of the entity, as well as relationship and much more things. So we designed the ER model using this. Now this ER model, consider this ER model is designed. Now on basis of this ER model, now what we do is ki from that ER model we derive a relational model. So in relational model what we do is ki relational model. So in relational model, basically the visual representation which we get, we break it into tables. So basically tables are drawn in ER model, relational model. Now for all these tables, we need to do some coding to make some tables, like to create tables, to insert data into tables and much more things. So that is done using SQL. So basically using SQL we create, insert, update and do much more operations on the data. Now coming to one-on-one relationship. So what happens in one-on-one relationship? Each row in one table is associated with one and only one row in another table and vice versa. So basically consider that there are two entities. Entity 1 is student. Let me just change the color. And entity 2 is course. Now student is having a relationship with course, that is enrolls. So student is enrolled in a course. Now this particular entities is having some attributes such as student ID, student name and age. This particular entity is having some attributes such as course ID, course name and course professor. Now in this particular entity, SID is the primary key, and in this particular entity, course ID is the primary key. Now these two entities have a relationship among them, that is enrolls. Now basically, can you see that enroll is also having an attribute? So what happens na ki enroll is having an attribute such as enrollment date. So enrollment date is present as an attribute for a relationship table. So what happens ki this particular table, whenever we draw table for the relationship, is called as junction table or associative table. Now coming to the doubts which would be coming in your mind. Now the very first doubt you would be having in your mind is ki we were having a primary key foreign key relationship in the relational models, right? So why do we need an extra table for a relationship? Because ultimately we were establishing relationship of primary key and foreign key between different tables. Now what was the need of introducing a relation table in the very first case? So basically this relationship table or relation table is introduced because consider that there are, as I told that there are four relationships: one to one, one to many to one and many to many. So in many to many relationship, what happens now? Ki generally what happens ki in this particular ER model, what happens ki there is two entities and one relationship. So there would be three tables. In those three tables, we generally find out the primary key and we just reduce that three tables into two. But what happens in many to many relationship? Now the tables can't be reduced. Right now you won't be understanding these terms. Again I would reiterate these terms after the many to many relationship video, but the first use case was that, and the second use case was ki what if the relation among two entities have an attribute of its own. So basically, as you can see, this enrolls is having an enrollment date as an attribute. Now the enrollment date can't be present in the student table as well and in the course table as well, because again it doesn't make sense to make the enrollment date or introduce the enrollment date field in student table or the course table. So basically enrollment date is something which is an attribute of the relationship itself. So for that also we need separate table. So basically, as you can see that since there are two entities, what we are doing is ki now we are breaking this ER model into relational model. So what we do while breaking? So there are entities, entity 1, entity 2. So for those separate entities, what we will do is we will draw a table. So basically this is a student table and this is the course table. So basically student table is having fields such as student ID, student name and student age. Course table is having fields like course ID, course name, course professor. Now course ID is having CID as primary key because it is uniquely identifying all the records in a table. Now student is also having a student ID as primary key. Again, it is also uniquely identifying all the records in a table. Now the third thing which comes is the relationship table. So basically this table is this one. So basically this is a enrolls table. So basically in this table what happens is we mention, like, see, as an individual, student is an entity, right? Course is also an individual entity. So from this table we are knowing, okay, student S1 is having name as Ram and age as 14. Here also we are knowing ki course ID is C1, course name is physics and course professor is Saurav. But are we able to know the relationship among these two? In primary key foreign key relationship, what we used to do is ki in the table, like in one table there was primary key and in another table that primary key was present as a foreign key, which was able to like grab the relationship or was able to make the relationship between these two tables. But right now you can see that SID is present here, CID is present here, but SID is not present in the course table. So there are no relationship between these two tables. So just to establish a relationship, we introduce the relationship table. So in the relationship table, what we do is we first write all the primary key of the student table, that is student ID, which is acting as a foreign key here. Now the primary key of the course table, that is CID, which is acting as a foreign key here, and then the attribute of this particular relationship table, that is EDate, enrollment date. Now student ID is given here, course ID is given here, EDate is given here. Now this one table we know that primary key is student ID. Now for this table also we know the primary key is CID. But for this table, what would be the primary key? Because again SID is also something which is uniquely identifying records in the student table. CID is also something which is uniquely identifying records in course table. Now among this, which could be the possible primary key? So among this, any of one could be the possible primary key, either SID or CID. Any one of them could be a possible primary key, because always for one student there is one course, and for one course one student is being enrolled. So one-to-one relationship, what happens is ki only for one particular student there is one course, or vice versa, only for one course there is one student which is enrolled. So basically the student won't repeat ever, the course won't repeat ever. So any of them, either student ID or CID, can be a part of primary key. So basically the very first question arises is ki in the relationship table, which is the primary key. So in one-to-one relationship, any of the attribute which is serving as a primary key in any of the entities can be the possible primary key for relationship table. Now the second question arises in our mind is ki can we reduce this table? So there are three tables. First one is for student entity. The second one is for relationship table or enrolls tables, and the third one is for course table. So basically there are three tables. Can we normalize, or can this table be reduced? So the answer is yes, the tables can be reduced. How these tables can be reduced? So consider, for now I am considering SID as a possible primary key. Now you can see SID is also present here. SID is also present here. Now S1, S2, S3, the values are not repeating. S1, S2, S3, the values are not repeating. And for now, like any of them, either SID or CID, any of them can be assumed as a primary key. For now I am assuming SID as a primary key. So basically what we can do is we can combine these tables into one table, and this table would be as it is. So what happens when we combine SID, SName, SH, that is of student table, and SID, CID, EDate, that is of relationship or the enrolls table. So basically SID is present here, which is common among both of them. SName is here, SH is here, CID is here, EDate is here, and then this particular table is here. So basically earlier we used to have three tables, now we used to have two tables. Let's re-revise all the concepts from the very starting. Now, what is one-to-one relationship? So one-to-one relationship is established whenever one row or each row of one entity is associated with one row or each row of another entity. So basically, one-to-one relationship means each row of one entity is associated with each row of another entity and vice versa. Now, in one-to-one relationship, what happens is that there is two entities and there is one relationship among them. Now, for all these three, we draw separate tables. So basically, ER model is now broken into relational model. So in relational model, we draw tables. So basically, we draw table for all these three: entity 1, relationship 1, and entity 2. Now, in all these three tables, we have first table is the student table, the second table is the course table. Now, student and course table stands as an individual entity, but when we want to establish a relationship between the student table and course table, we introduce the relationship table. In the relationship table, we add the primary key of student table, we add the primary key of the course table, which is acting as a foreign key because again it is referencing to primary key of another table, and this one is also referencing to primary key of another table. Along with that, we add the attributes if they are present for the relationship table. Now, what happens is the first question which comes into mind is what would be the primary key of the relationship table. So basically, from first table, that is student table, we get the SID as primary key. From the second table, that is course table, we get the CID as primary key. But in the relationship table, what would be the primary key? So any one of them, either student ID or course ID, can act as a primary key. Now, the second question which comes into mind is can we reduce these tables, because again there are three tables and the relationship table is having a primary key from existing student table also, existing course table also. So can we combine those tables or can we reduce the tables? So the answer is yes, we can combine or we can reduce the tables. Again, we can combine those tables, like consider in relationship table, for now we are considering student ID as the primary key. So we can combine relationship table with the student table having student ID as a primary key. If we are taking course ID as primary key, then we can combine course table and the relationship table, which reduces our tables from 3 to 2. So basically, this was all about one-to-one relationship among different entities. Right now, we are reading about ER model. So ER model basically means entity relationship model. So the relationship between two entities and the visual representation of that, or you can say the designing of that, is called as ER model. Now, as the name suggests, entity relationship. So there would be some relationship between different entities. Now, what is entity? Any living thing or any living object is an entity. Now, they would be having a relationship between them. Now, entities is having relationship among them. Consider there is an entity A and there is an entity B. Consider the entity A is customer. Consider the entity B is the order it makes. Now, there would be a relationship between customer and orders. What could be the relationship? Customer, place, order. So place is a relationship between these two. Now, there are some mapping constraints which are present when we establish a relationship between two entities. So what is this mapping constraint? Mapping constraint are things like one customer can place only one order. That is one-to-one mapping constraint. One customer can place many orders. That is one-to-many mapping constraint. So basically, the relationships or the connections or how these entities are being mapped in the relationship is called as mapping constraint. And there are various types of mapping constraints such as one-to-one, one-to-many, many-to-one, and many-to-many. So today we would be knowing all about one-to-many. So I guess without any further delay, let's get started with the lecture. So one-to-many relationship. A database model where one entity on one side of the relationship is associated with multiple entities on the other side, it is called as one-to-many relationship. So basically what happens in a database model, when one entity is associated with many other consider that there is one record which is associated with many other records in the other side, or you can say in the other entity, then that is called as one-to-many relationship. So let's see from an example and understand from an example. So there are two entities. First one is an author entity, entity E1, and second entity is the book entity, that is entity E2. Now author reads book. Reads is the relationship between these two entities. Now, there are certain characteristics of entities that is called as attribute. So, here are attributes such as author ID, author name, and author age. Here are some attributes such as book ID, book name, and book type. Now in this author ID is the primary key, in this book ID is the primary key. Now here the relationship is also having an attribute that is called as booking date or publishing date. Like author publishes books, so what could be the publishing date? So basically these attributes are called as descriptive attributes. So whenever the relationship is having an attribute, that is called as descriptive attribute. So here there are two entities, a relationship between two entities. First entity is having some attribute or some characteristics. Second entity is also having some attributes and characteristics. There is one relationship that is also having an attribute such as publishing date or booking date. Now what happens in real life is now whenever we design a database or whenever we have been given some requirements and we design a database, so what happens is the first step is we get the requirements. Okay, these are the requirements. Second is we get the schema. So basically schema like person and the attributes or characteristics of person such as person name, person age, etc. Now from this schema we draw the ER model. That is basically the visual representation of data. And now after ER model there comes a relational model. That is basically from this visual representation we implement it in tables. And to do it physically we use a language to do the physical implementation. We use a language that is called as SQL. So this is the format which goes ahead. So now I have the requirement, I have the schema, I have drawn the ER model. Now I'll turn the ER model into relational model, that is into tables. So how I'll form the tables? So I'll pick the first entity, entity E1. I'll draw the table for author. Now for the author I'll mention all the characteristics. So basically characteristics are given in the columns. So author ID, author name, author age. Now I'll fill some data in here. Now here it is given that author ID is the primary key. So I'll mark author ID as the primary key. So basically this is the table for the author entity. Now coming to another entity, that is book entity. So this is the book entity and this is the author entity. So in the book entity also now I go ahead with the characteristics. I give them in the columns, book ID, book name, book type. Now I'll provide some random data for all these as of now. And then since primary key is book ID, so book ID is something which would be unique for every record. Here also author ID is something which will remain unique for every record. Now this table is done, this table is done. Now I am coming to the relationship table, that is reads table. So what will be there in the relationship table? So basically relationship table is something now which is establishing a relationship between two entities. This entity can alone tell me details about the author. This entity can alone tell me the details about the books. But I don't know now which author has published which book. So basically in the relationship table what happens is the relationship which is defined or which is established between two entities, we mentioned that. So how the relationships established, you may have learned about primary key and foreign key relationship. If you haven't, I have uploaded a video on the same, so you can go ahead and have a look. So basically I'll give the primary key of the author table here, I'll give the primary key of the book table here, and the descriptive attribute of relationship table, that is B date or B. This is not B type, this is B date. So this is B date. So I'll give the descriptive attribute, I'll give the primary key here, and I'll give the primary key here. Now these both would be acting as a foreign key. As I told now, what is foreign key? Foreign key is a key which take reference from primary key of another table. Basically establishes a relationship between two tables. So foreign key establishing a relationship. So in the relationship table, that is read table, I am taking a foreign key which is directly pointing towards the primary key of the author table, and then BID is a foreign key which is directly pointing towards the primary key of the book table. So basically they are establishing a relationship. So the very first question which comes in mind is, okay, what would be the primary key in the relationship table? Because in the author table, AID was acting as a primary key. In the book table, BID was acting as a primary key. But in the relationship table, which among these two would act as a primary key? So basically what happens now, this is a one-to-many relationship. One-to-many relationship means that one author can publish many books. So one author can publish many books. So basically A1 is an author which can publish B1 book. A2 is an author which can publish B2 book. A3 is A1 is again an author which can publish B3 book. So as I told now, one-to-many. So one author can publish many books. Either he or she can publish B1, B2 or B3. Now author 2 can publish B4, B5, B6. So one author can publish many books, but one book is published by only a single author. So if there is B4, it is published only by A2. If there is B1, it is published only by A1. So one author can publish many books, but one book is published by only one author. So what happens is that author ID is something which can be repetitive, like author 1 can publish B1 book, author 1 can again publish B3 book, author 2 can publish B2 book. So what happens is that you can see na कि there is duplicacy, or you can say कि A1 is repeating two times. For first time A1 is repeating for B1, second time A1 is repeating for B3. So A1 is something which cannot uniquely identify the records in the table because it is not unique. It is coming two times, maybe it can come 3 or 4 times. So what we do is कि generally in the many side, the primary key always lies. So what is the many side? Books is the many side. So one author can publish many books. So one author can publish B1, B2, B3, then other author can publish B4, B5. So basically one author can publish many books. A1 can publish B1 and B3. So book ID is something which is unique, but author ID is something which is not unique. So book ID is the primary key in case of the relationship table. So you can just think in this way that primary key always lies in the many side. So whenever there is a many side, the primary key would be lying only there. So book ID is the primary key. Now the second question which comes into mind is, can we reduce these tables? So let's see about this. So this is the author table. This is the book table. And this is the reads table. Just now we knew that BID is the primary key in the read table. Now author ID is the primary key here and BID is the primary key here. So yes, the answer is yes, we can reduce the table. How we can reduce the table? So you can see now in this particular reads table and in this particular book table, the primary key is same. BID is a primary key here and BID is also a primary key here. So what we can do is we can combine these both tables and we can make one single table. So author would be a single table, that is one table, and book table along with read table can be a second table. So basically from 3 tables we have reduced to 2 tables. So when we will combine these 2 tables, what we will do is first we will give the primary key, that is BID, B1, B2, B3. Now we will start with the attributes. So B name is here, B type is here, now AID is here and B date is here. So basically the combination of these two can give me a table, and BID is something which would remain unique for both the tables. So BID will be coming one and then these AID, B date, B name and B type would be there. So basically from 3 tables we have reduced to 2 tables. So just summarizing. So one-to-many relationship means that whenever one entity is associated with many records in the other entity, that is called as one-to-many relationship. Now in one-to-many relationship, in the relationship table, primary key always lies at that side where there is a many relationship. So basically whenever there is 1 to n, consider that there is a customer and it has a relationship with order 1 to n. So where there is the n side, that is in the order side, the primary key will always lie there. Now the second thing is, can we reduce the table? Yes, we can reduce the table, because again in the relationship table, primary key is something which is common in the relationship table as well the entity table which is on the other side. So we can combine those tables. So from 3 tables we can reduce to 2 tables. As I explained about one-to-many relationship, it's just a reverse of that, but we would be discussing about some normal concepts like what would be the primary key, would the table be reduced, if the table are reduced, how many tables are in the final response, and many things. So without any further delay, let's get started. So many to one relationship. Let me just re-revise one to many relationship once again. So consider there is an entity E1 that is having a relationship with entity E2 in a one to many fashion. So what happens in one to many is E1 can be associated, like one record in E1, consider book. So book can be associated with many authors, A1, A2, A3. Now book B1 is associated with many authors. Book B2 can also be associated with A4, A5, A6. So when we simplify it, you can see B1 is associated with A1, B1 is again associated with A2, B1 is again associated with A3. So basically one book is associated with many authors. So this is one to many relationship. Now same in the case of B2. We can see B2 is associated with A4, A5, A6. Now again it is one to many relationship. Now in many to one relationship, it is just the reverse of the same. So in many to one relationship, what happens is that many authors can be associated with one book. So it's like author A1, author A2, author A3 can be associated with one book, that is B1. Now author A4, author A5, author A6 can be associated with one, that is B2. So basically it's a reverse of one to many relationship. So many to one is just a reverse of one to many relationship. Now let's understand from the definition. So a database model where multiple entities or records on one side of relationship are associated with a single entity or record on another side, that is called as many to one relationship. So let's understand from an example. So in the example, you can see that there is a entity employee, that is E1. There is an entity department, that is E2. Now E1 is having some characteristics such as EID, ENAME, EH, that is also called as attributes. E2 is also having some attributes such as department ID, department name, department type. Now E1 is having EID as the primary key. E2 is having DID as the primary key. Now according to this, many employees, just let me draw it here. So many employees can belong to the same department. So whenever you are working in a company, there is a department like such as development department, there is an HR department, there is some other departments. So many employees can work in the development department, many employees can work in the QA department, many employees can work in HR department. So many employees, that is N, can work in single department, that is 1. So when we simplify this, we get E1 is working in D1, E2 is also working in D1, just a second, E3 is also working in D1. So you can see that E1, E2, E3, that is many employees is working in the same department. So let me just write it here, E1, E2, E3 all are working in D1 department. Now we draw the tables for employee. Consider that this is the table for employee. We draw the table for department. This is the table for department. We draw the table for relation. So this is the table for relation. Now the relation table would be having the primary key of employee and the department. So it is having the primary key of employee, that is considered EID, and it is having the primary key of department, that is DID, which is now acting here as a foreign key, these both. Now the very first question arises, what would be the primary key in the relation table? So just think, what could be the primary key in the relationship table? So here from the diagram you can see that this is from the employee and this is from the department table. Now these both are present. Now you can see that employee E1, E2, E3. So employees are unique. So that is what this means is that employee can uniquely identify records in a table. Consider any attribute of employee. So it can uniquely identify records in a table. EID is something which can uniquely identify all the records in a table. But when I am coming to department, that is DID. So one department would be having one department ID. Consider that soft engineer is having E as department ID, HR is having H as department ID. So here you can see that every employee is working in E department. So whenever I am making a query in the database using key, okay, give me the employee who is working in E department. So again, it will give me many employees. But if I make a query key, okay, employee, give me the details about employee E1. So it will give me the specific details about that employee E1. But whenever I'm making query using the department ID, it will give me like any random employee, right? So what we do is we make this EID as the primary key. Also, you can remember in such a way that whenever there is a many relationship on whichever side, that entity primary key is the primary key in the final table. So basically many side is always having the primary key. So in the many side, that is EID. Now the second question is that there would be 3 tables. Now can we reduce these 3 tables? Again the answer is yes, we can reduce the 3 tables because EID is the primary key here. And EID is also the primary key here. So 2 tables are having the same primary key. So we would just combine these 2 tables. So we would combine the employee and work, and department would be 1 table. So now 3 tables are reduced to 2 tables. So many to many relationship. As the word suggests, many to many means this particular entity would be also having many records here, and this particular entity would also be having many records here. So let's understand with the definition, and then we will jump in the example and discuss more concepts on this. So a database model where multiple entities records on one side of relationship. So consider that E1 and E2. So multiple entities and record of one side of relationship are associated with multiple entities or record on another side of relationship. Consider this as C1. Okay, so there is 2 entities, E1 and C1. So this is C1, C2 and C3. So where multiple entities or record on one side of relationship are associated with multiple entities or records on other side of relationship. So that is called as end-to-end or many-to-many relationship. So let's understand from an example. So consider that there are 2 entities, student and course. So according to this ER diagram, many students can opt many courses. So basically there are many students. Consider Ram, Raj, Rahul. For now I am only taking 3 students. So Ram, Raj, Rahul are the students, and the subjects which are present in the school are Hindi, English and Maths. Now coming to Ram, Ram can either opt Hindi, can also opt English, and can also opt Maths. Raj can also opt English or Maths. Rahul can also opt Hindi or Maths. So basically Hindi is being opted by Ram, Hindi is being opted by Rahul. So you can see na ki in first go Ram is opting Hindi, English and Maths, and in the second go Hindi is being opted by Ram and Rahul. So at the first go we can see that there is a one-to-many relationship. At the second go you can see many-to-one relationship. So when they are combined, one-to-many or to one, so it results into many-to-many relationship. Now here you can see there are 2 entities, student and course. Student is having some attributes or characteristics such as student ID, student name and student age. Here student ID is given as primary key. So right now we are seeing that what requirements we are given. So all these things are given to us. So student is having attributes student ID, student name, student age. Course is having attributes course ID, course name and course professor. Relationship is also having an attributes such as enrollment date. Now they are having a many-to-many relationship among them. Student ID is the primary key for the student table. Course ID is the primary key for the course table. Now this is the visual representation of the DB. Now we will draw it in the form of tables, that is the relational model. Now first we will drop for the student table. So student is having student ID, student name and student age. I have given all the details, and student ID is the primary key. I have provided that. So student, that is a base table I have drawn. Now here for entity 2, course is the table. So course table is here. Now course is having attributes such as course name, course ID and course professor. So course ID, course name, course professor. Course ID is given as primary key. So this I have drawn as a primary key. Now for the relation table, I am having an attribute as enrollment date. So for now, just consider that I have given only this attribute in the relation table. Now what happens is from this particular table I am getting details about what is student ID, what is student name, what is student age. From this particular table I am getting details about what is the course ID, what is the course name and what is the course professor. But I am not getting the exact relationship, because see, entity relationship, what happens is we establish relationship between entities. Now in these two entities which individually exist, we have to establish a relationship. And to establish a relationship, what we do is we pick the primary key from the first entity table, we pick the primary key from the second entity table, and in the relation table we mention both the primary keys. So from the primary key we can know okay, there is an employee E1 who is from department D1. There is an employee E2 who is from department D2. So all those details we can know from the relation table. So here I have given the primary key of student table, that is SID. Here I have given the primary key of the course table, that is CID. Now since this primary key, this key is kind of taking reference from the primary key of another table, so this is called as foreign key. This particular key is also taking a reference from another table, so this is also a foreign key. Now the very first question which arises in our mind is for this one though we are sorted. For the student table or the base table we are sorted, SID is the primary key. For course tables also we are sorted, that CID is the primary key. But when there is a relation table, what would it be the primary key in this particular case? So in this particular case what happens now? I have told you that primary key always lies in the many side. But here though both are many, like the relationship is many to many. So where the primary key would lie? So as I told this is a many to many relationship. Many students can opt many courses, and many courses are opted by many students. So there is a many to many relationship. So student S1 can opt for course C1, student S2 can opt for course C2, student S3 can opt for course C3, again student S1 can opt for course C3, again student S2 can opt the C3 course. So you can see now what is happening is SID is also something which is kind of repeating. So you can see S1 is repeated here, S1 is repeated here, S2 is repeated here, S2 is repeated here, and here also C1 is here, C3 is here, C3 is again repeated, C3 is again repeated. So there is repetition. Yeah, I do agree that in the student table, student ID was acting as a primary key, and in the course table, course ID was acting as a primary key. But in this particular table, we can see that there is a repetition in the student ID as well and in the course ID as well, as many students can opt many courses and many courses can be opted by many students. So what we do in this particular case is we make student ID and course ID combined as a primary key. So why we are focusing more on primary key? So whenever we are having a primary key, the query becomes very easy. So if you are having a primary key, you can just give that particular primary key and you can make a query key. Give me the details of student whose student ID is A, B, C or 1, 2, 3 or anything. So in this particular case, again if I give the student ID is 1, 2, 3. So student ID 1, 2, 3 has also opted C1 course, student ID 1, 2, 3 has also opted C4 course. So student ID is not something which can act as a primary key. Again CID is also something which cannot give me uniquely identified records. So what I do is I combine student ID and course ID in this particular relationship table to be a primary key, so that if I query using student ID and course ID, I can get the details for a particular student. I can get the student name who has student ID as S1 and who has course ID as C1. I can get the student name who is having the student ID as S2 and course ID as C3. So I can get to know about all the courses student has opted and what all students are present there. Like the query becomes much more easy and useful whenever we are having a primary key. So the first question was what would be the primary key. So in this particular case, the primary key would be the combination of both foreign keys or the primary keys from both the table. Now the second question which comes into our mind is, can we reduce these tables? So in one-to-one, one-to-many and many-to-one relationship, we were able to reduce the table because in two tables the primary key was same. But here you can see SID is the primary key. Here you can see CID is the primary key. But here SID and CID, sorry, it's not BID, CID. So SID and CID are combinedly acting as a primary key. So the answer to this question is no. Be reduced. So the answer is no, the tables can't be reduced. So the total number of tables would be 3 and the primary key would be the combination of foreign keys, or you can say the primary key from E1 entity plus the primary key from E2 entity. So since we have completed all the mapping constraints, let's just re-revise once again in a very quick go that what are all these one-to-one, one-to-many, many-to-many and many-to-one relationships. So let's start from one-to-one relationship. In one-to-one relationship, what happens if the records in the first entity is associated with the records in second entity in one-to-one manner. That is, one record in one entity would be associated with one record in entity 2. So consider that there is a person and there is a PAN card. So for each person there would be one PAN card. So person P1 is having a PAN card as C1, person P2 is having PAN card as C2 and person P3 is having a PAN card as C3. So this is one-to-one relationship. The very first question is, what would be the primary key of relationship table? So primary key can either be the one from the E1 table or primary key can either be the one from E2 table. So any one of them can act as a primary key. Now the second question is, can we reduce the tables? So the answer is yes, we can reduce the tables and we can combine the tables. The two tables like the relation table and the table which is having the primary key same as the relation table can be combined and 3 tables can be modified into 2 tables. Now the second relationship is one-to-many. So whenever one record in the entity is associated with many records in another entity, that is called as one-to-many relationship. So consider person and mobile number. So one person P1 can have mobile number like can have many mobile numbers. So one person P1 is having a mobile number as M1 and one person P1 is also having a mobile number as M3. Now P2 is having as M2. So this is called as one-to-many relationship. Now again the same question, what would be the primary key of the relationship table? So the primary key would always lie at the many side. So mobile number is the many side. So a primary key would always be in the mobile number side. So primary key would be the one which is acting as a primary key in the mobile number side. Now second question is, can we reduce the table? So as of now we have 3 tables: person, has, mobile. So the first table, base table, then the second table, then the third table, relation table. Yes, we can reduce the table. So tables can be reduced. So primary key would be lying at the many side. So we can combine this has and mobile into 1 and person would be 1. So basically there would be 2 tables after reduction. Now the third one is many to one. Now many to one, again many books can have a single author. So B1 is also having author as A1, B2 is also having author as A1, B3 is having author as A2. So in many to one, again what would be the primary key of relation table? So the primary key of relation table, again the primary key which lies in the many side, that is the primary key in the book table, would be the primary key in the relation table. Again, can we reduce the tables? So there are 3 tables: book, written by author. So primary key right now is lying inside the book, so we can combine this book and written by, that is this relation table, and we can combine it into 1. So there would be 1 table this and there would be 1 author table. So 2 tables. So we can reduce the number of tables. Now the last is many-to-many relationship. Again, the example is student and course. One student can opt many courses can be opted by many students. So again, this is a many-to-many relationship. The first question is, what would be the primary key of relation table? So the primary key of relation table would be the primary key of student table plus the primary key of course table. So there would be a combined, or that is also called as composite key. That is 2 primary keys. Now second is, can we reduce the table? So the answer would be no, we can't reduce the table, because again there is a composite key, there is a composite primary key. So since composite primary key is existing and for different entities there is only one primary key, so we can't combine the table, so reduction of tables is not possible. So why we are knowing about this participation constraint, ER relationships, entities, attributes and much more things. So what happens now, consider in a very vague way, you have been given an API to design. So what you will do, the very first thing is you will know the requirements, what are the requests of your API, what would be the responses of your API and much more things. Now second, you would be asking for a LLD diagram, that is a low level design diagram, because your API is internally calling this particular clients and this particular manipulations are done inside. So you will ask for the LLD. Once you get the LLD diagram, you would just implement the code and then the API would be working. In the similar way, what happens is whenever we are designing any database, we first get the requirements for the database, that what are the entities in the database, what would be their characteristics and much more things. Once we get all the entities, the primary key, the attributes or the basic requirements, we go ahead and draw the ER model using that entities, then establish a relationship between entities and draw all about the characteristic, the relationship and much more things. Now once we are done with the ER model, that is the visual representation of our API, what we do is we go ahead and draw the tables for that, that is the relational model. So we draw the tables for all that particular design or all that particular visual representation we had. Now for that particular tables to show in our laptop or to show in our database, what we do is we use a programming language for the same, that is SQL. So here also what we are doing is since we are knowing more about ER model, and as I told in the very end of this ER model series, or you can say in the very end of this ER model topic, we would be designing a model for Instagram. So basically whenever we are designing such a huge database, like Instagram is having such a huge database, or any social media or any delivery platform which is having such a huge database, they have many things, like they tend to use some of the best practices, they tend to use or they tend to do the code reusability, they avoid the data inconsistency and much more things. So here also comes into the picture the participation. Now what is the participation constraint? Let's go and understand. So from the definition, participation constraints in ER model define whether every entity in one group must be connected with at least one entity in another group, or if the connection is optional. So what happens in the participation constraint? As you know that in ER model we basically deals about entities and their relationship. Consider that there are two entities, they are having a relationship among them. Now what kind of relationship they are having? We have learnt about what kind of relationship they may be having, strong relationship, weak relationship, how they are internally mapped. We have learned about mapping constraints, one to one, one to many, many to many and many to one. Now in this particular video we are knowing about what is the participation of that particular entities. So if two entities are together in a relationship, how they are participating? Is each record in one entity is participating with another record in present in another entity? So what kind of participation? So basically from the participation constraint you can understand from the word itself how entities are participating in the relationship. We deal about that in the participation constraint. So whether every entity in one group must be connected with at least one entity in another group, or if the connection is optional. So there are two types of participation constraint. One is total participation and second one is partial participation. So partial participation is called as optional, and total participation is this in which one entity in another group must be connected. So must be connected is the total participation and optional is the partial participation. So let's learn about these two participation. So the first participation is the total participation. So what happens in total participation? In total participation constraint, each entity in a participation set must be associated with at least one entity in the related entity set. So what it says is कि each entity in the participation set. So this is the participation set. And this is the related entity set when we are seeing from the department point of view. So whenever we are seeing from the department point of view, department is the participation set and employees is the entity set. Now here you can see there are two entities, employees and department. Employees having some attributes or characteristics in which EID is the primary key. Department is also having some attributes and characteristics in which department ID is the primary key. Now you can see here I have given a single line, but here I have given two lines. So basically these two lines means the total participation. So what it says is that employee works in a department. So every department would be at least having one employee. Consider that there are many engineering department, HR department, sales department and much more. Consider today I am making one more department, XYZ. So if there are no employees in this department, does this department makes any sense? So in the same way that in each department, there would be at least one employee. So department is having a total participation with employee, that in each department there would always be an employee. But it's not true that each employee would be working in a department. There could be some more employees which doesn't work in a department. They just come on a contract basis or something like that. So there could be a possibility that every employee is not associated with department, but every department must have a employee. In the same way, you can also take an example of this relationship. Consider that there is a customer who borrows loan. So there are two entities, loan and customer, and borrow is the relationship. Now every customer borrows a loan. So consider there are loans L1, L2, L3. So L1 may be associated with one customer, L2 may be associated with one customer, L3 may be associated with one customer. But there won't be any loan which is not associated with any customer. How come there is a loan for which there is no customer, right? So loan would always be having a total participation with customer. But for customer, there might be some customers who are not taking loan, who are not having any loans. So customer can exist individually or can have a partial or optional participation, that not every customer needs to have a loan, but every loan is somehow associated with one customer. So in the partial participation, in partial participation constraints, entities in the participating entity set may or may not be associated with entities in the related entity set. So if we are seeing from the employee's point of view, this is the participating set and this is the associated entity set, or you can say related entity set. Now, not every employee from the participating set should be associated with related entity set. So not every employee should be present in all the departments or a particular department. Every department should have an employee, but not every employee should be a part of any department. In the same way, every customer can borrow loan, or loan is something which is associated with every customer, but there may be some customers who don't wish to borrow loan, right? So in this example, not every customer is borrowing loan. Some customers are borrowing loan, some customers are not, but each loan is associated with one customer, because there can't be any loan which is not associated with any customer. So these extended ER features comes into picture now, because what happens is sometimes when we are drawing the ER model or when we are drawing the entities, there might be a possibility that the structure becomes so complex. There is no code reusability. There is some data inconsistency which is also occurred. So to get rid of all these, to lessen the complexity, to increase the data consistency and much more things, we come with the extended ER features. So let's see about this. So again, the question is, why do we need? We design ER model for relationship between entities. Now in the real world, the data may exhibit some hierarchical relationships, and the EER, that is Extended Entity Relationship Model, provides the mechanism to represent these relationships accurately, which helps in code reusability, ensuring data integrity and consistency, and lowering the complexity. So, in the real world, consider that there is a person. Now, person may have some attributes such as name, age. Now, this person may be acting different roles at different platforms or different areas. So, this person may be a student. So, student may have details such as student ID, student Aadhaar card, or something like that, or student subject. Now, this person may also be, when he or she is like doing some online shopping or doing some taking some orders or giving some orders, may also be acting as a customer for any of the website. So, when the person is customer, it may have customer ID, customer order detail, and much more thing. So what is happening now? There is one entity person which is now being overburdened with all the attributes such as name, age. Now there is student Aadhaar, student subject, student ID, customer order ID. So what happens in this case now? We just split it into different subgroups such as customer and student. And now the attribute which is common among both, that is name. So name stays with the person. Just a second. Name stays with the person. Some attributes such as age, which is also common for person, customer, and student. So it remains the same. But when we are coming to customer, there are some distinctive attributes which only customer have, student doesn't have. So such as customer ID. So customer ID stays with the customer, and for student subject. So in this way, what is happening now? We are subgrouping the entities into different entities. So these kind of things like hierarchical relationship which is being established. So you might have seen in inheritance that there is a superclass and there is some subclass. So in inheritance, what happens is the subclass or the child class inherit all the properties present in the superclass. In the same way, the person is having name and age, which is now inherited with customer and student. But now student and customer also have their distinctive attributes such as student ID and customer ID. So basically in this extended ER features, we would be seeing three features. First one is specialization. Second one is aggregation, and third one is generalization. Let me just give you an overview about all these three. Then we would be separately looking about all these three in details in next set of videos. So in specialization, what happens? As I told, that person may have some overburdened attributes because person may be acting as a customer, person may be acting as an employee, person may be acting as a student. So person entity all alone may be having many attributes. So what we do is we subgroup person entity into different entity, such as person may be subgrouped into customer, employee, student, so that the attributes are not overburdened to the person, and also customer, employee, student may have their distinctive attributes. So that is called as specialization. In this we do a top-down approach, and it follows the concept of inheritance. Now coming to the second one, that is aggregation. Now aggregation, from the word, it means aggregating something. So what happens in aggregation is sometimes there are some relationship which is ternary relationship. So more than 3 entities are involved, or n relationships in which more than 3 to 4 or 5 many entities are involved. So when there are involvement of more than 2 entities, or there are involvement of more than degree 2, then what happens the structure becomes very complex. So when the structure becomes very complex, what we do is we aggregate the higher level entities, and then we establish a relationship between 2 entities. So in aggregation, what we do is we do abstraction of the higher level entity into one entity, and then we establish the relationship. Again, if you're not understanding, no worries, we would be looking in depth about all these in the next set of videos. Now in the generalization, what happens? So in generalization, consider that there are two entities. First is the saving account, second one is the current account. Now this saving account and current account may have some attributes which is common among saving account and current account. So why not to make a generalized attribute, that is account, which would be having account number and account name, which is present in the saving accounts as well and current account as well. So basically in specialization, we are just identifying the subgroup entities. In generalization, using that subgroup entities, we are guessing the generalized attribute, so generalized entity. Now what is specialization? So as explained in the earlier video, what happens is, consider there is an entity person. So let's take an example of entity person. Now person is an employee as well when it's working in a company, a student as well when it's working in or when it's studying in a college or school, and is a customer as well when he or she is doing some online order or online buying. So person acts as an employee, student and customer. Now what happens is person is having some attributes such as name, age. Now coming to customer, customer may have some attributes such as customer ID, customer order details. Now coming to student, student may have student ID, student subjects. Now coming to employee, employee may have employee ID, salary and much more thing. So what is happening now, this person entity is getting overburdened with many attributes. So what we do is we split or we subgroup the person entity into different sub entities such as employee, student and customer, and the attributes which are same in all these three, that is name and age, stays with the person, and the distinctive attributes which is not common among employee, student and customer such as employee ID, student ID and customer ID is provided to them. So what happens, specialization is, in specialization in ER model is like categorizing entities based on the common features. A super type group of entities with shared attributes and relationships, while subtypes have their own unique attributes, that is EID, SID and CID, and the shared attributes are name and age. So a super type group entities with shared attributes and relationships, while subtypes have their own unique attributes and relationship. It's a way to organize data efficiently. It is a top-down approach. So as you can see now, person is being subgrouped into employee and student. So it is a top-down approach. It is basically following the inheritance way, that there is a superclass and there are some subclass which is inheriting properties from the superclass. So let's understand from an example. So here it is a person. Okay, I just missed the last line. We have a relationship between the superclass and the subclass. So person is the superclass and employee and customer are the subclass. And there is a relationship, is a relationship between person, employee and customer. So person is the employee as well as customer. Now person may have some attributes, that is age and name, which is common among employee and customer, but employee ID, employee salary and customer email and customer IDs is something which is distinctive. So in the super type, all the attributes remain shared, which is like shared in the child classes also or the subclasses also, and in the subclass there are attributes which are distinctive. So this is specialization. Basically in specialization what we do is we subgroup the entities into different groups, like person is subgrouped into employee and customer. Person may have some attributes which is common between employees and customer, but employees and customer may have some distinctive attributes. So generalization. Generalization is like finding things that are alike and putting them into a bigger group to represent what they have in common. It helps making things simpler and organized. Now in specialization what we were doing is consider there is a person. Now we were subgrouping the person into customer, employee and consider student. Now in generalization what we do now, consider that we have these subgroups, student and employee. Now a student may have some attributes like name, age or something like that. Employee may have some attributes as well. So what we do is we make a higher level of entity, that is person, which would be kind of having the common things in student and employee. So in specialization we were identifying the subgroup entities, and in generalization we are identifying the generalized entity. So it is a bottom up approach, as student and employee together are forming a person. So it is a bottom up approach. We have is a relationship between the subclass and the superclass. So this is the superclass and this is the subclass. So let's understand from an example. So here in the example you can see there is electronic device. So consider that I have two entities. First one is mobile phone and second is laptop. Now mobile phone may have some attributes and laptop also may have some attributes. So consider mobile phone is having an attribute such as battery. Mobile phone may have memory, then it may have mobile ID and it may have the mobile type. In the similar fashion, laptop may have laptop ID, laptop serial number. Again, laptop also would be having an attribute such as memory and battery. Now you can see memory and battery is an attribute which is common in both of these, mobile phone and laptop, and it is a general attribute of an electronic device. So what we do is we make a generalized entity, that is electronic device, which would be now extending battery as well as memory, and we remove this battery and memory from here, and we remove this battery and memory from here as well. So what we did is we generalized some of the attributes which was common in the sub entities. So this is what we are doing in this diagram as well. There is a electronic device, laptop and mobile is having a relationship with the electronic device, as it is a bottom up approach. Electronic device is now having memory and battery, and laptop have their distinctive attributes such as laptop serial number, laptop ID, and mobile type. So this is generalization. So basically in the specialization, what is happening in the specialization, we have an entity and we provide some subgroup entities which have some distinctive attributes. In generalization, what we do, there are some subgroup entities which are having some common attributes. So we make a higher level of class, or we do an abstraction of a higher level of class which would be having all the common attributes or common characteristics these two would be having. So there is one more thing in extended ER features. First one is attribute inheritance and second is the participation inheritance. So in attribute inheritance, what it says is that both specialization and generalization exhibit attribute inheritance. What is this? Consider there is a person who is having some attributes. So employee and student who is inheriting person would be having the same attributes. So it inherits the same attributes. In participation, what it says is if parent is participating in some relationship, so child would also be participating in that relationship. So consider person is a parent and employee and student is a child. So if parent is participating in any relationship, employee and student would be participating in the same. Now there is one more feature of extended ER, that is extended entity relation, that is aggregation. Now let's understand what aggregation is all about. So aggregation is like stacking things on top of each other to create a structure. It is used to create a hierarchical structure in data modeling, showing how a higher level entity is composed of lower level entities. So basically in aggregation, what happens now? We have heard about relationships and types of relationship, like binary relationship, ternary relationship, and more. Like if more entities are involved, then there are more relationships. So what happens now? Whenever there are more than two entities which are being involved, there is a complexity which is increased very much. So when the complexity increases, it's very difficult to understand the ER model as well. So what happens whenever there is a ER model which is extending the degree to, or extending or being a ternary relation or more complex than that, what we do is we generally create a hierarchical structure showing how a higher level entity is composed of lower level entities. So what we do is, with that lower level entities, we make a higher level entities and try to generalize or try to make it in such a way that it again comes in a entity to entity relationship. So this may sound confusing right now. Let's understand from an example first. So abstraction is employed to view relationship from a more general perspective, focusing on a higher level entity. So we basically use the abstraction concept and we make the lower level entities as one entity, which is a higher level entities, and in that higher level entity there is a relationship among different entity. So this is the ER model which is present before aggregation. So there is an employee which works in a department, is also having a job, and now this employee also manages a department because this employee is a manager. So consider there is a company. Now in company there are many employees. Some employees are developers, some employees are QA person, some employees are HR person, and there is a manager who manages a particular branch or a particular department in a company. Now that particular manager is also serving as an employee. That particular manager is also having a job. That particular manager is also managing the department. So what is happening here is that employee is working in a department, is also having a job, and now employee is managing the department, that is called as manager. So you can see that there are many entities involved and this ER model is kind of complex. So what we do in aggregation is that we combine these lower level entities into a higher level architecture. So in a higher level, what we do is that we segregate all the lower level entities into one complex architecture. So we segregate all the lower level entities into a high level architecture. Now what it shows is that employee works in a department, is having a job, and employee manages as it is a manager. So basically what we are doing is that we are segregating all the lower level entities into a higher level architecture, and then we are establishing the relationship. So this whole is treated as entity 1 and this whole is now treated as entity 2. So there is a relationship between entity 1 and entity 2, that is entity 1 manages entity 2. So basically manager manages the department in which manager is also working as an employee and having a job. So in aggregation what happens is that whenever there is a relationship or whenever there is a ER model in which the degree is extending to, what happens, there is a complex architecture. So just to break down that complex architecture into some simple architecture, what we do is that with that lower level entities, we combine all the lower level entities into one higher level architecture, and then we establish the relationship as we establish between two entities. So steps to draw an ER model. Till now we have learned all the things about ER model, like what are entities, types of entities, strong, weak, then types of attributes, complex, composite, multi-valued, then coming to the relationships based on cardinality or degree, that is ternary, binary, and much more, based on mapping constraints, that is 1 to 1, 1 to many, many to 1, and many to many, then about total participation and partial participation, then extended ER features. All of things we have known. So we would be knowing about how we can draw an ER model. So the very first step is recognizing the entities. Now consider you have given a problem statement that you have to draw an ER model for Myntra app. So you have to identify all the entities which are there. So the very first step is recognizing all the entities, such as if you are drawing an ER model for library. So there would be some library department, there would be some book type, there would be an entity of book, there would be an entity of details, there would be an entity of all the details of when you are publishing the book, when you are returning the book, and much more things. So there would be some entities, so you need to identify all the entities. Now the second thing is that when you have identified all the entities, now you need to know all the characteristics or all the attributes of that particular entity. Consider again taking that library example, there is a book. So book may have book ID, book author, book issue date, book submission date, and much more things. So we need to specify the characteristics or identify the attributes. Now the third step is discover connections and relationship, also constraints like mapping and participation. Now we need to discover the relationship that library has books. So there is a has relationship, that library has books. Now there are some mapping constraint that what it would be the relation 1 to 1, 1 to many, many to many, or many to 1. What would be the participation constraint? Either is it a total participation or is it a partial participation? Now in the fourth, we are defining the connection types, that how entities are connected or cardinality. Again, based on degree or the mapping constraints, we identify that if it's a one-on-one relationship, 1 to many, many to 1, many to many, total participation and partial participation. Now in the fifth way, what we do is now we construct an ER model. Now we are ready to construct an ER model. We got the entities, we got the characteristics, that is attributes, we got the relationship among entities. Also we got that what kind of relationship they have, what kind of participation they have, what kind of mapping they have. Like we got all the details. Now we can go ahead and design the ER model for the same. So construct an ERD, that is entity relationship diagram. Now the sixth step is annotate relationships and attributes. So there may be a possibility that there is a derived attribute which would be represented like this. There may be a possibility that there is an attribute which is a primary key which would be represented by this. There may be a multi-valued attribute, there may be a composite attribute. So we have to annotate the relationships and attributes. The seventh step is review and refine the model. So again, you can use that extended ER features whenever you are seeing that the complexity is increasing. You can use that extended ER features, that is specialization, aggregation and generalization. Now document the model. So you can also go ahead and document the model, that what all things you have done. Like you can document that library has a relationship with books, books has a relationship with the details, or books has a relationship with students who are taking the books, like these. So you can document all the relationships which books have, which library has, which student has, in a proper documented format. Now you can validate that document with the stakeholders, that is my understanding correct, that there is a one-to-one relationship, the entity is having 3 attributes, among which one is the composite attribute, and the relationship is one-to-one or one-to-many, like this. And the 10th step is implement the database schema. So now you can go ahead and implement the database schema, or you can go ahead and formulate the relational model or formulate the tabulated model for the same. Before moving forward, I would like you guys to know what Instagram is. So yes, it's a lame question because 99.99% of the people would be knowing about Instagram. But just for the people who are not knowing, or just to give you a short revision about it. So Instagram is basically a social media platform where you upload your picture, where you upload images, videos, stories, have friends like followers, then you follow your friends, which is called as following, then you upload your profile picture, then you have some bio, and there are much more things which is there in Instagram. So Instagram is a social media platform that allows user to share photos and videos. Now, what all things are there in Instagram, or what all things we can do on Instagram? So the first thing is creating our own profile. So everything starts with creation of a profile. So we create our profile. Then we add a profile picture and some details like your bio, that where you are working right now, or if you are a musician, you can mention that you love playing music or singing, or you love playing guitar, and much more things you can mention. Now the third thing is connection with your friends, or connect with your friends. So basically on Instagram, whenever you are done with the profile creation and whenever you have uploaded your picture and some bio about yourself, then you can start connecting with people. You can upload a post, you can like and comment on different posts, share stories, and much more things are there. So why right now I am explaining about this is because I want you guys to have a basic idea about how Instagram functions, what all things we can do on Instagram. On basis of this, we would be formulating an ER diagram. Now let's start with all the steps which are needed to draw an ER diagram. So the steps which I told you in the last video, we would be going step by step and we would be formulating an ER diagram. So there the step 1 was recognizing all the entities. So here the entities are user profile. So user might be having a profile. I told na ki firstly what happens is ki user create a profile. So there is a user profile which is created. So user profile is the first thing. Now when the user profile is created, he or she will upload the profile picture, add some details about them, and then will start connecting with friends. So the second thing is user friends. So the second entity here is user friend. Now the third entity is we have created a profile, we have connected with our friends. Now we would like to upload some photos or videos. So the third is user post. The fourth entity is user login. So whenever you go to any social networking platform like Facebook, LinkedIn, Instagram, so there you get a login page where you enter your username and user password, and then you are redirected to that particular social media platform where you can see your profile and timeline as well. Now the fifth entity is user likes. So if you upload your post, there might be some people who would be liking your post. If you are connected with some of your friends, you would also be liking their post or commenting on it or sharing it on different social media platforms or sharing it on your story and much more things. So these are the 5 entities. As of now, I have taken these entities into consideration because again, if I increase the number of entities, the ER model diagram would be very complex and it's not impossible to include all the entities, all the attributes in the same model or in the same diagram. So as of now, we are seeing a template which we can follow for a ER model of Instagram. So these 5 entities are right now recognized as the entities which we can use further in the ER model. Now the second thing is specify entity characteristics or attributes. Now we have specified that what all entities are there, like user profile, user friends, user login, user post, user likes. Now we need to identify what are the attributes or what are the characteristics of that particular entity. So first we'll start with user profile. So in user profile, there is a user ID, there is a username, there is an email, and there is a profile pic. Now user ID is serving as a primary key because it can uniquely identify records in a table. The second is username, which is a composite attribute. So composite attribute, what it means, ki username can also be further divided into sub attributes like user first name, user middle name, and user last name. Email is a single valued attribute. Profile picture is a single valued attribute. DOB is a stored attribute. Stored attribute again is something which is stored, and derived attribute is something which we derive from the store attribute. So here user ID is the primary key, username is the composite attribute, email is a single valued attribute, profile pic is a single valued attribute, DOB is a stored attribute, and age is a derived attribute. Now coming to entity number 2, that was user friends. Now user friends have these attributes such as follower ID, follower name, and user ID. Now you can see user ID. You have seen that user ID in the user profile as well, right? And it is present here as well. So there is some kind of relation which is present between user profile and user friends. So if a primary key of one table is present in another table and referencing it, that is called as foreign key, which we have learned in the last videos. So we would be having a good look on this in the ER model diagram. Right now, consider that user ID is right now acting as a foreign key, which is referencing to the primary key of the user profile. Now user friends is having a follower ID which is serving a primary key for this particular table. Now follower name, which is a single valued attribute, and user ID, which is also a single valued attribute. Now the third entity is user post. Now user post is having a post ID, a caption about the post, or if you post any image then there would be a caption, image, video, likes count, and timestamp, the time at which you have uploaded your picture or the time at which you have posted your picture or videos. So post ID is acting as a primary key for this particular user post table. Caption is a single valued attribute. Image is multi-valued because you have seen that sometimes in one post there are many images. So there could be many images which could exist in single post. So that is why it is a multi-valued attribute. That is, one attribute may have multiple values or multiple things. So video is again a multi-valued attribute. Likes count is a single value attribute. It would be in numbers like 1000, 2000. Timestamp is also a single valued attribute. Now coming to the fourth entity, that is user login. Now user login is having a login ID, login username and login password. Now in this, the login ID is serving as a primary key, the login username is a single valued attribute and the login password is a multi-valued attribute. So coming to the fifth attribute, this is fifth, is the user likes. So user likes is having a post ID and user ID. So here post ID is serving as a primary key and user ID is a single valued attribute. So now you would be seeing there are some of the attributes which are being repeated in some of the tables, like user ID is also repeated. Post ID is something also which is repeated in the user post and user likes table. So again, there is a repetition of attributes because these attributes are somehow serving as a primary key in one of the table and in other table to establish the relationship they are serving as a foreign key. So what foreign key does is कि foreign key help us to establish a relationship between two tables. When we go forward in the video, you would be having a more better understanding. So for now, just you can understand from this way कि if you are seeing some repetition of attributes in different tables, so there could be a possibility that one table is having a relationship with different tables. So in that different tables, there is a attribute which is present, which is serving as a primary key in table A and right now is serving as a foreign key in table B, table C or table D. Now the step 2, discover connections, relationships, also constraints like mapping and participation. Now we have to discover the connections and linking or the relationship between them. As I told like right now only na, कि what happens is कि we use the primary key to establish a relationship between two tables. Now we have also learnt about the relationships, like types of relationships based on cardinality or mapping constraint, that is one to one, one to many, many to many and many to one. So on the basis of that, we will now establish the relationship between those entities. So the very first step was to identify the entities. The next step was to identify the attributes or the characteristics of all those entities. And the third step is to establish the relationship between the entities, to know the mapping constraints, like how they are mapped with each other, one to one, one to many to many or many to one. Now here, the first relationship is user profile will have user friends. So n number of profiles can have n number of friends. Now the second one is user profile have user post. That is one user profile can have n number of posts. So that is 1 to n relationship. That is user post will always be associated to user profile. Therefore, there is a total participation. I also explained about types of participation. You can have a look on the earlier videos and then you can come and have a look on this particular video. So the third one is user profile has user login. Now one user profile always have one user login. So consider that there are two profiles which is created. One I have created, one my sister has created. Again, my sister would be having different username and different password. I would myself be having different username and different password. So there is a 1-to-1 mapping. Now the fourth is user profile has user likes. So one user profile can like many posts, like there are many friends of mine, so I am liking every post uploaded by them. So one user profile can have number of likes, like many number of likes. So user likes will always be associated to a user profile. Therefore, there is a total participation. Now the fifth is user friends have user post. So user friends can also upload some post, right? So user can consider that there are multiple user profiles. User profile 1, user profile 2, user profile 3. User profile 1 and user profile 3 are friends in, like they both are friends. So user profile 1 can also upload many photos. User profile 3 can also upload many photos. So user friends may have user post. That is 1 to n relationship, that one user friend can upload many posts. So it will also be associated to a user profile, therefore total participation. So why this total participation term is coming every time? So what happens now, कि there is a user friend, right? So if there is a user, only then a user friend would be existing. If there is no user, then user friend is associated with whom, right? So user friend is existing only when there is a user which is existing. So therefore there is a total participation. Now user friends has user login. So user friend can also have a user login. Again, it would be in a one-to-one manner, because one user friend can have a one user login, another user friend would be having another user login. So it is one-to-one fashion. Now seventh one is user friends has user likes. So user friend can also like other photos, can like their own photos, can like other friends' photos as well. So that is one-to-one relationship. And again here user likes will be associated to a user profile, therefore total participation. So again, if there is no user profile which is existing, then user likes doesn't make any sense. So there should be at least one profile which should be existing so that we can count the user likes. Now this is the ER model of Instagram. I know it is a bit complex, but let's understand from the very beginning. I'll make sure that you understand each and everything, and even if you don't, please watch the video again and the steps to design an ER model video as well, because that video is also very important video in terms of understanding. Again, there are terms like total participation, strong entity, weak entity, multi-valued attribute, composite attribute, that wouldn't make any sense if you don't watch the earlier videos. So first watch all the earlier videos and then you can come here and then have a look on the ER model of Instagram. So let's start. So let me just switch it to this one. Okay, so we will start with user profile. Now user profile is an entity. User profile would be having username, user ID, email, profile pic, DOB and age. So here I have mentioned it. So the user profile is having user ID, username, email and profile pic. Now user ID is serving as a primary key, so we have underlined this. Email is a single valued attribute, profile pic is a single valued attribute, age is a derived attribute and DOB is a stored attribute. So in this way we represent the stored and derived attribute. And here username is serving as a composite attribute. So when there is a composite attribute, it is an attribute which can be breaked into subparts. So username is now breaked into first name and last name. So this is about the user profile. Now user profile has some relations. So the very first relation is user profile have user post. The second relation is ki user profile has user likes. The third relation is user profile has user login. So first start with user profile has user login. So now user profile has user login. Every user would be having only one login details. So there is a one-to-one relationship. Now user login is having some of the attributes such as login ID and login name. Login ID is here serving as a primary key. Now coming to the second relation, user profile have user post. So user profile have user post. So user profile, one user can have multiple posts, right? So there is a one-to-n relationship between them. And in the user post here you can see there are some of the attributes such as post ID, image, timestamp, video and caption. Now caption here is working as a single valued attribute. Video here is right now a multi-valued attribute. Why so? Because multi-valued attribute is an attribute which can have multiple values. So there could be multiple videos for a single user, right? So in the timeline you can see for a particular user you can find multiple videos and multiple images. So here video is working as a multi-valued attribute. Image is also serving as a multi-valued attribute. Timestamp is a single valued attribute and post ID is here serving as a primary key. So we have made it underline. Now coming to the third relation user profile has. So user profile have user friends. Now you can see that I have made it two rectangles. Why so? Because here the user friend is a weak entity. So we have read about strong entities and weak entities. Why user friend is a weak entity and why a user profile have user friends is a weak relation? Because if there is no user, there wouldn't be any user friends, right? So it all depends on user. If there is no user, there won't be any user post, there won't be any user likes, there won't be any user logging or something like that. So for now, just to make you or to give you more clarity about weak and strong entities and weak relationship, I've used this here just for an example, right? So when you are asked to draw an ER model in the interviews, you can go ahead with the basic template only, but when they ask you to specify everything like the strong entity, weak entities, total participation, partial participation, then you can go ahead and point out everything that this is a weak entity, and you can give an explanation why this is a weak entity. So again, user profile and user friends have a end-to-end or many-to-many relationship, because many user profiles can have many friends. Same way, many friends can have many user profiles. So here user friends is having a user ID and follower name. Now you can see user ID which is present here as well and here as well. Here user ID is working as a primary key in user profile table, and here user ID is somehow establishing a relationship between user profile and user friends. So it is acting as a foreign key which is helping to establish relationship between user profile and user friends. Now user profile have user post. This I have explained. So this relationship is explained, this relationship is explained, this one is explained. Now coming to this relationship. So now user profile has user likes. So again, a user profile can like many posts or can have many posts which can be liked by a particular user. So that is one to many relationship. Now user likes is also having one user ID which is serving as a foreign key which is helping to establish relationship between user profile and user ID. And user like is also having a post ID as a primary key. Now again, user post can also have user friends, like user friends can also have user posts. So there is 1 to n relationship between user friends and user post. User friends can also have a user login. So there is also a 1 to 1 relationship between user friends and user login. And I guess, yeah. So user friend can also have a user likes. So there is also 1 to n relationship, that is one friend can have many likes. So there is 1 to n relationship between them. So this is all about the ER model of Instagram. Again, it is very complex to understand, but right now I have taken very less entities and very less attributes to make you understand it at a very clear picture. If you are asked in an interview to draw or design an ER model of, consider Facebook, consider LinkedIn, or consider Threads, so you can use this particular ER model as a template, but always think about all the important entities which you shouldn't miss, because again there are many entities and you can't take all the entities, all the attributes and draw an ER model. You have to pick some of the few of the entities which are important according to you, few of the attributes, and you have to draw an ER model. Also do take care to follow all the design patterns, like if there is a multi-valued attribute, there would be 2 circles. If there is a derived attribute, there would be a dotted circle. If there is a weak relation, then there would be 2 diamonds. If there is a weak entity, then there would be 2 rectangular boxes. So always make sure to mention all these, because all these things would really help you and the interviewer as well to understand that you have a very great knowledge about ER model and DBMS. So we read about ER model in the last set of videos. Now here we would be knowing much more about the relational model. Now why we are knowing about all these models, how it is helping us, and why we should be knowing about relational model, tables, relation, and much more things. So what happens now? You are given a requirement. Consider you are given a requirement that you have a banking system. Okay, so now what you will do is, firstly you will draw the ER model for the banking system. Now secondly, you will convert this ER model into relational model. So in the ER model, we basically deal with the visual representation. And in the relational model, we deal with the tabular representation. And when we are done with the relational model, we will choose a software using which we can insert all the datas, do some manipulation on that data, or perform some CRUD operations. So this is how the flow goes. Now in this particular video, we are learning about relational model. So what is relational model? It is a way of organizing data into tables. Now what happens is ki consider there is a banking system. Now for that banking system, I have given a visual representation of that banking system using all the entities, all the attributes. Now from that visual representation, what I am doing is I am using that visual representation to convert it into a tabular format. So basically conversion or organizing data into the form of tables is called as relational model. Now there are some terms which are mostly used in the relational model. The first one is table, which we called as relation in the relational model. The second is row, which we called as tuple in the relational model. The third is column, which we called as attribute in relational model. The fourth is record, which is each row in a table. The fifth one is domain, which is the type of value an attribute can hold. Sixth one is degree, which is the number of columns in a relation. And seventh is cardinality, which is the number of tuples. Let's understand from an example. So this is a table. Now the table would be having some rows and some columns. So the columns are called as attributes in the relational model. The rows are called as tuple. And each row is called as record. Now the table itself is called as a relation. Now domain. So consider that this is the attribute which is name. Now name can only have character values. Consider this is the attribute which is age. So now age can only have integer values. So we are giving the domains of both of the attributes. Now the sixth is the degree. Degree is the number of columns in a relation or attribute. So you can count 1, 2, 3. So the degree here is 3. And cardinality is the number of tuples or the number of rows. That is 1, 2 and 3. So cardinality is also 3. In the ER model, cardinality basically means the mapping constraint that was 1 to 1, 1 to many to many and many to one relationship. But in the relational model, cardinality basically means the number of tuples and degree basically means the number of columns. Now, what is relational model all about? So, relational model is all about data being organized into tables, establishing relationship between tables using foreign key as I explained earlier, maintaining the data integrity. That set of rules should be there that if there is a attribute which is called as age, in that attribute I shouldn't fill the value as ABC. So there should be some integrity constant which should be present, and there is a domain that is integer. Only integer values are accepted here. If I insert other values apart from integer, it will give me an error. And then the fourth one is a flexible and efficient way to store data which is using the SQL and to retrieve data. So these all four things combines gives us the information about relational model. Let's have a look on what all are the things we take care in the relational model. So the first thing is maintaining the integrity constraints like domain, entity and referential integrity. Now consider that there is a table person. Now person is having attributes as name, age and date of birth. Now there could be a possibility that someone inserts a wrong value in the age. Consider ABC. So there are some integrity constraints which make sure that we don't insert any data apart from the domain. Now the second is the value should be atomic, that can't be divided further. So whenever we give the attributes or whenever we provide the attributes in the relational model, that all the values should be atomic. It shouldn't be that I am giving a multi-valued attribute in a table. So if I am giving a multi-valued attribute, consider that there is a username which is a multi-valued attribute. So while making the table, I shouldn't give it as username. What I can do is I am making the table and here I'll give the user first name, here I'll give the user second name or middle name, and there I'll give the user last name and then the other attributes, which means that all the values should be atomic, that it can't be further divided. Now the third is each row must be unique, and here the keys comes into picture, that is candidate, super and primary. So converting an entity relationship, that is ER model, into a relational model involves several steps. So let's start with step 1. Step 1 is identifying the entities. So first, list down all the entities like the strong entity and the weak entity. In the entity video, I told you about the strong and the weak entity. So you can go ahead and watch that particular video. It would be, I guess, like it would be 10 lectures behind. So you can have a look on that. For your convenience, I'll give the link in the description itself. So here you can see that there is a ER model of a person which is having a relationship with address. Now the person is having some characteristics or attributes, that is ID, name and age. And here ID is acting as a primary key for the person table. Now person is a strong entity. Coming to address. So address is having attributes such as city, flat number and street. Here address is a weak entity. Why address is considered as a weak entity? Because consider that there could be a situation that there is no person. So if there is no person or there is no existence of person, does address plays any role? In a similar way, like there is student and there is a course. If there are no students who would be taking the course or who would be studying in that department. So basically address here is serving as a weak entity and person here is serving as a strong entity. Now when there is a relationship between strong and weak entity, that is called as weak relationship, which is indicated by double diamond, and whenever there is a weak entity, it is indicated by double rectangles. So what happens is when there is a strong entity, we mention all the attributes of the entity to formulate into a tabular format. So basically person would be a table which would be having columns like ID, name and age, where ID is serving as the primary key. But in case of address, which is a weak entity, what we do is, since strong entity and weak entity are establishing a relationship between them. So I've told you earlier what happens is whenever we need to establish a relationship between two entities, we use the foreign key concept. What does foreign key does is, the foreign key is a key which helps to establish relationship between two tables. It serves as a primary key in the table A and it serves as a foreign key in the table B. So whenever table A and table B wants to have a relationship between them, what they do is, if table A is having a primary key, it took that primary key and make it a foreign key in table B, so that table A and table B have the same attribute which can help to form a relationship between these two tables. Now in address table, what we are doing is, we are mentioning the primary key which is from table person. Then we are giving all the attributes such as flat number, street and city. Here flat number is acting as a primary key. Generally in weak entities there is no concept of primary key because again the entity itself is weak, but there is a unique identifier and we called it as primary key. So here ID plus flat number both would be acting as a primary key, because ID here is acting as a foreign key which is referencing to the primary key of another table, and flat number is acting as a primary key for this address table. So basically there is a composition of ID and flat number, that is why it is called as a composite key. And this composite key is serving as a primary key for the address table. So whenever we would be making a table for both of these entities, strong and weak, in the strong entity we would be giving all the attributes along with the primary key. In the weak entity we would be giving the attribute which is a foreign key which references to the primary key of strong entity table. Along with that we will mention all the attributes, and the primary key for this table would be a combination of the primary key of this table and the foreign key of this table. So now the step 2 is identifying the attributes. Now again I told you that attributes can be of many types like stored, derived, single valued, multi-valued, composite. So whenever there are such type of attributes in ER model, how we will go ahead and design it in a tabular format. So first thing what we will do is we will differentiate the entities. When we differentiate the entities, per entity there are some attributes or there are some characteristics for that entity. So consider that this is the ER model where we are talking about employee and department. So they have a relation that employee works in a department. Now employee is having a composite attribute, that is name, which is further divided into first name and last name. Employee is also having a multi-value attribute, that is phone number. So one employee can have two phone numbers, primary or secondary. And here ID is serving as a primary key. Then there is a department which is having department ID as the primary key for this particular table and department name as a common attribute or a single valued attribute. So let's take the case of name, which is right now serving as a composite key. So what we will do is whenever there is a, okay, just a second, I guess I have named it wrong. So this would be a composite attribute and this would be a multi-valued. Okay. So coming to the composite attribute. So consider that this name is a composite attribute. Now whenever we want to draw a table for this employee, what we will do is we will mention this employee. Now we will start mentioning the attributes, that is ID. Now for this composite attribute, what we do is we mention all the composite attributes, because again in relational model what I have told you values should always be atomic. There shouldn't be any value which is not atomic. There should be only atomic values which can't be divided further. So here the last name and first name we are giving as it is, employee first name, employee last name. So we have eliminated this attribute name with employee last name and employee first name. Similarly, if there are any more composite attribute, we will eliminate that particular attribute and we will mention all the sub attributes. Now coming to the multi-valued attribute, that is phone number. Now in phone number what we will do is there would be a table with all these things, ID, employee name, employee last name and everything. Along with that there would be another table, because in multi-valued attribute what happens is we are saying that one employee can have different number. So consider that I am formulating this in a tabular format. So there is an employee ID and there is a phone number. Okay. So consider that there are employee IDs 1 and 2. Now I am saying one is having a number 919 and one is also having a number 929. So again I can't put the attributes like this because this row should have only one value. So either it will lead to the duplicacy, that I am again duplicating employee ID and here I am giving 929 rather than here, or else what I can do is I can make a separate table where I can give the employee ID and the phone number. So here what happens is this table will remain the same with ID, employee first name and employee last name. But for the multi-valued attribute, what I will do is I'll make a new relation with the primary key which is present here and the attribute which is a multi-valued attribute. So there would be a new table for the same. Now the step 3 is the key selection. Choose the primary key for each table. For some, it can be in a form of composite key, as I told in this example of weak entity, where the primary key is in the form of composite key, that is composition of keys. Now the step 4 is if entities have a relationship, break it down and reduce the number of tables if possible. So you have seen in the last video where we made an ER model for Instagram. So there you have seen that there were many relations between user post, user profile, user friends. So basically there are one-to-one, one-to-many, many-to-many and many-to-one. On this I have made a video that what happens that if there are two tables which is having one-to-one relationship. So can we reduce that tables? If the tables can be reduced, where the primary key would exactly lie. So again, if there are two entities and they have a relation between them, there would be 3 tables. First one would be entity 1 table, second would be the relation table, and third would be the entity 2 table. And what happens was entity 2 table or the relation table combines sometimes entity 1 table and relation table combines. So about this I have made a dedicated video, you can have a look on that as well. So whenever there is a one-to-one relationship, there would be 2 tables and primary key can lie on any side. So consider that there is a relation between employee works for department. So when there is a one-to-one relation, so there would be 2 tables for employee and department and third table for relation. Now consider that there is a one-to-one relation, so there would be a employee ID which would be acting as primary key here. There would be a department ID which would be acting as a primary key here. So for the relationship table to deduce, what we do is we combine these 2 tables or these 2 tables, any of the table we can combine and we reduce it to 1 table and there is 1 table. So basically 3 tables are reduced to 2 tables. Now when there is one-to-many relationship, So whenever there is a one-to-many relationship, what happens is that primary key always lie into the many side. So relation table and the many table always combines, and this table remains the one, and these two table combines into one. So there is again two tables where primary key lie on the many side. Now when there is a many to one relationship, just reverse of this, two tables and primary key can lie on many side. When there is a many to many relationship, three tables would be there, because again this table may have some attribute which is associated with this table, and this table also may have some attributes which is associated with these tables. So there is no common thing between them. So there would be a three tables, and primary key always lie in the relation table, which would be a combination of primary key from this particular table and primary key from this particular table. So what is intention? Intention defines what kind of data can be stored, basically the data type and the relationships between them. So whenever we discuss about what kind of data that can be stored in a table and what kind of relationships table can have in between them, that is called as intention. Now this is basically the blueprint or the definition of the database structure. So basically in the definition of database, we mostly tell that what kind of tables would be there, what would be the data which would be present in the tables, basically the data type, the constraints the table would be having. So it basically tells us about the database structure. Now it doesn't change frequently, and it's permanent definition of the database structure. So it doesn't change frequently, because consider that if we have a huge database of employee. Now in this employee database, we might be having a employee details table, and one about employee previous work history table. So employee work history table. Now in these certain tables, there is like very less addition of new columns, or you can say new set of attributes which are being introduced. So there is not a kind of permanent change which happens very frequently. So that is why it is told that it is a permanent definition, because the changes are not very frequent. Yeah, maybe there could be a possibility of adding one more or two more new attributes or column, but that doesn't occurs very frequently. It's very rare. So that is why it is called as the permanent definition of database structure. Now it includes the very first thing, table definition. So what table definition is? Basically the name of tables, their columns, and the data type allowed in each column. So in a database, you can have multiple tables. What is database? Database is basically collection of data. And tables is basically an intersection of attributes and tuples, or you can say rows and column. So here there could be multiple table T1 and T2. So what is this particular table name, along with what all are the data types of the data which is being stored, then what are the constraints which are provided to this particular data, that all things we discuss in intention. Now the second thing is constraints. So constraints are basically the rules that governs the data, such as primary key, foreign key, and data validation rules. So constraints basically allows that if this particular data is being stored, does it follow this particular rule of a primary key constraint? Does the column shouldn't hold any duplicate values because it is having a primary key constraint. If it is having a not null constraint, it shouldn't take any null values. So that type of validation rules are performed. Now the third one is relationship between the tables. So there could be a relationship between the table, like foreign key primary key relationship, wherein one table is having a shared column with another table. There is one foreign key which is present in one table, and there is one primary key which is being referenced by that foreign key in another table. So there is also a relationship which is established between two tables of databases. Now here is an example. So here we have taken an example of a customer table. So this is the table name. These are the table attributes, or you can say column, table columns. These are the data types of the attributes or the table column, so you can say data types. So this proves our first point, that it includes the table definition, that is name of table, their column, and data types allowed. Now the second thing which you can see here is a constraint, which is a primary key constraint. There is a rule on this ID column that ID should always hold unique as well as not null values. It can't hold any duplicated values because of this primary key constraint. So it also proves our second point, that is it includes constraint. Now the third one is relationship between tables. Since here we are discussing only about one table, we don't know that if there are more tables in the database which is existing. So for now I haven't given any foreign key or primary key relationship, but consider that if there are two tables, there could be a possibility that a primary key in first table can be acting as a foreign key in second table, establishing a foreign key primary key relationship between the tables. So in this way a relationship is also defined. So intention basically consists of table name, the constraint it has, the data type it has, the column name it has, basically the structure of the database or the structure of the tables which is present inside our database. It is the intention in database. So let's see what is extension in database. The extension is the actual data that is stored in database at a given instance in time. So whenever we see the actual data which is stored in database at a given time, that is called as extension. Basically the data which is stored in tuple or rows at a given instance of time. When there are more tuples added, the data can change. So consider that at a time t1, I am looking at my employee table. In this employee table, I can see there is ID, name and department. And there are entry of 3 people, Rahul, Afsara and Abhimanyu. Now company hire new individual. So whenever they will hire new individual, the tuple or the row would be filled with new values. Now if I see my table at time t2, I can see that there are 4 entries in my table now. So our entry for Aditya is newly added at time t2. So at time t1 I was seeing then there were only 3 people. Consider after 5 days if I am seeing, I can see that there are 4 people now in that particular employee table. Consider that after 10 days if I am seeing the table, I can see that there are 5 entries in the table. So Raj is also added newly. So at particular instance of time, the data which is present in the database is called as extension in database. So extension in database is not permanent because there would be more number of employees who would be added. There would be some employees who would be also leaving the company. So the extension doesn't remains permanent, but intention is kind of permanent because in that we basically define the table structure or the table definition. So extension is basically the actual data which is stored at a given instance in time. Intention is the table structure or you can say table blueprint. Now before learning about RDBMS, let's learn about database and database management system. So what is database? Database is basically collection of data. So whenever we have a collection of data, we call it as database. Now what is this database management system? It is a software application to manage our data, or you can say to perform CRUD operations on our data. Now consider that we have a lot of data in our database. Now we need to manage that data basically whenever we want to do some creation in the data, some updation in the data, some insertion in the data or some deletion in the data. So for managing all those CRUD operations, we need a software which will help me to manage my data which is present in the database. So that is DBMS. Consider that there is a user. Now user wants to manage a database. So it will use a software application to manage that database, and that particular software application is called as DBMS. Now databases are of 2 types. First is relational database and second is non-relational database. Now what are the differences between them? So relational databases basically use table to store data. So whenever we are using tables to store our data in databases, we call it as relational databases. The example are MySQL, Oracle and MariaDB. Now what is non-relational databases? So whenever the data is not stored in tables, we call it as non-relational databases. The example is MongoDB. So they could be stored in key value pair or some different thing, but they are not stored in the form of tables. So relational databases are the database which is stored in the form of tables. Non-relational databases are the database which basically follow some other pattern like key value pair or some other pattern to store the data. So just now we learnt about relational databases. Now what is a database? Database is basically a collection of data. In that particular database, there could be multiple tables, T1, T2. What is relational database? Relational database is a database in which data is stored in the form of tables. Also the tables which is present inside the database can have a relationship between them. So that is why it is called as relational, because the tables inside the database can establish a relationship between them. So this is relational databases. Now to perform CRUD operations or to manage data of the relational database, we need a software. So that software is called as relational database management system. So whenever we use a software to manage data of relational databases, we use this relational database management system. So these database structure data into organized table that have some predefined connections or relationships between them. Data manipulation and querying are performed using SQL. So we use SQL, that is structured query language, to perform any kind of data manipulation or query in our data which is present in our database. So we use this as a programming language to perform any kind of CRUD operation. So here if you see, there is a user. Now user is using a software application. So in terms of relational databases, we use RDBMS. Now an example of RDBMS is MySQL. So basically MySQL is a software which helps us to perform the CRUD operations, and SQL is the programming language which we use to do some manipulation or querying in the data. So MySQL is the RDBMS and SQL is the programming language which we use to perform the queries. Now this is the database on which we perform the query. So this was all about relational database management system. In one word, relational database management system are the softwares which help us to manage the data which is present in relational databases. Now in relational database, data are stored in the form of tables and they have some connections or relationships between them. So now normalization is quite important in terms of semester exams, but it is also asked in interviews as well, like tell about normalization, what are the types of normalization, what is denormalization. So this is an important topic, so don't skip this video. Always have a clarity about what normalization is, what are the types of normalization in terms of interview point of view. So let's understand about normalization. Now, normalization is a process in which we organize the data to reduce redundancy, that is duplicacy of data, and improve the data consistency, that is same set of data is present across each databases. So it involves dividing a database into two or more tables. Now what is normalization? Consider that there is a table of employee which is having employee details such as employee ID, employee name, employee department name, employee department ID, and employee department phone number. Now there is a table of employee which is having all the details such as ID, name, department ID, and department phone number. Consider you enter the details of first employee. So employee ID is 1, name is Riti, department name is IT, department ID is 01, and department phone number is considered +91 something. Now again you are asked to insert details of second employee who is in the same department. So you go ahead and insert the detail of the second employee. So here employee ID would be 2, the name would be considered Raj, the department name is IT, the department ID is again 01, and the department phone number is the same which is given above. Now here can you see that this department name, department ID, and department phone number is something whenever we insert any details of the employee who is in IT department is getting repeated. So here also we are repeating IT, department ID, department name. Here also we are doing the same thing. Consider that there are bunch of employees who are in IT department. So we have to do this repetition each and every time whenever we are inserting any of the employee details who is working in IT department. So what happens here is now, consider that if you want to update something, that the department ID is considered now 02. So you have to go ahead and update for each and every employee separately. So it is kind of increasing the duplicacy in the database because same set of data is getting inserted each and every time and it is a duplicate data. So what we do here is we introduce a concept of normalization which says that if you are facing any duplicacy of data or any inconsistency of data. So what is data consistency and how this data can be inconsistent? Consider that the department ID is 02 now for IT. So you updated it here, you updated it here. Consider that there are n number of employees who are working in IT department. And if you miss out to update for any one of the employee, it will show the department ID as 01 for that employee, but that employee is working in IT department. So that would be an inconsistent or you can say incorrect data. So that is why we can see that whenever we make a table which is having like details of employee ID, employee department details as well, we can see that there is a data duplicacy as well as data inconsistency, or the data consistency is very less. So because of that, we introduce the concept of normalization. Now what is data redundancy and consistency and why it's important? So whenever there is a same set of data repeated at each and every time, it results in the duplicacy of data. That is the same set of data IT01 which is getting repeated each and every time. So which is resulting in the duplicacy of data. Now row level duplicacy can be removed by using primary key for unique values. Now there are two types of duplicacy which happens. One is column level and one is row level. So here you can see that for certain columns, department name, department ID and department phone number, these all values are getting repeated for some certain number of columns. So this is called as column level duplicacy. Now coming to row level duplicacy. So in row level duplicacy, what happens? Consider that there is ID and there is employee name. So here you give the ID as 1, the name as consider Riti. Again you are giving the ID as 1 and the name as Raj. Again you are giving ID as 1 and name as Rahul. Like for employee it won't happen, but consider for school database or for college database, there could be a possibility that there are two people who are having the same name. So how you are going to differentiate between that two people? Because again, ID is something on basis of which we are differentiating the name. So if I am giving roll number 1 to Rahul Kumar and roll number 1 to Rahul Raj as well, so how I'll differentiate it, which Rahul is this, Rahul Kumar or Rahul Raj? So that is why we introduce the concept of primary key. We will make sure that all the values which is present in the ID column, if we are making it a primary key, is unique as well as not null. So whenever we make sure that this is unique and not null, what will happen that the ID is 1 for Riti. Now the ID can be anything apart from 1 for Raj and ID can be anything apart from 1 for Rahul. So this particular thing is now sorted because now we are getting unique values, and in terms of ID I can find that which person is this. Like if I say that ID is 2, I can surely say that this is Raj. If I say ID is 3, I can surely say that this is Rahul. So basically on basis of ID, we are somehow eliminating the duplicacy which was happening in each and every record for ID being 1. So in this way, we remove the row level duplicacy. But whenever we are encountering any column level duplicacy, for that we take the help of normalization. Now, whenever we have some data or some set of columns, it leads to different anomalies, or you can say inconsistency or error that occurs when manipulating or querying the data in the database. So as I told, consider that if you want to update department ID, so maybe you updated for each and every value, but some of the values were left. So there is a data inconsistency. Consider what happens is there is a new set of employees who come to our company and all these employees have left. So if I delete the data of Riti and Raj, we will lose the details of the department name, department ID and department phone number, because I don't have any separate table where I have all the details, like if it is a IT department, what is the department ID and what is the department name. And consider that if I want to somehow insert some data, then again it will be same duplicacy which will happen for each and every employee for whom I am inserting the data. Like the same thing, IT01 and phone number would be repeating for them. So that leads to anomalies. Now what are the anomalies? First is the insertion anomaly, second is the updation anomaly, and third is the deletion anomaly. Also, it increases the size of database with the same data. Now again, the same set of data is getting repeated each and every time. So it is increasing the size of database, because every time I have to give IT, department name and department phone number each and every time. So somehow it's increasing the size of our database. It's increasing the data duplicacy, or you can say the redundancy. It is causing data inconsistency as well. Now these are the anomalies which happen whenever we have some redundant, or you can say duplicate data and inconsistent data. Now let's learn about each and every anomaly and understand that how this anomaly occurs. So let's learn about very first of the anomaly, that is insertion anomaly. It occurs when it is difficult to insert data into the database due to absence of other required data. Now what does this mean? Consider a very lame example that there is a student who took an admission in a particular school. Now student is going to take admission in class 6, but right now he doesn't know that he is going to be in class 6A, 6B, 6C. Like in which section student is going to get admitted, he doesn't know. He only knows that he is taking admission in class 6. Now in 6A there are different set of teachers who are teaching. In 6B also there are different set of teachers. In 6C also there are different set of teachers. Now again, this particular student doesn't know that which particular teacher would be teaching him or her. And again, the class teacher would also be different for each of the sections. So all these details the student who has just taken an admission doesn't know. But we want to insert the detail of the student in our student database. So for all these fields, like what is the section, what is the teacher name, what is the class teacher name, we have to keep it as empty or null, because right now we don't know that what are the values or who are the person who is going to teach, what is the section in which student would be admitting in. So here also I have taken an example that consider you want to add a new department, but there is no employee in the department yet. So consider that in our company, there is a new department which is being introduced. There is IT and HR department, but now there is a supply chain department. Now for the supply chain department, this is a very new department which is being introduced. So I know the manager name of this particular department, I know the salary of this particular department. But as of now, there is no employee who is working in this particular department. So I have to keep all these values as null, and I have to only insert the department values, because right now in this particular table, we are having all the details of the department as well as all the details of employees. But right now, since this is a very new department, none of the employees is assigned to this particular department. So for now, these all values would be null. So this is called as insertion anomaly, when it is difficult to insert data into the database due to absence of other required data. Because consider that if ID is a primary key, I can't keep ID as null, right? Primary key, what it says is, if an attribute or a set of attributes is declared as primary key, it will always be unique as well as not null. But here we have to insert null value, because right now in supply chain department, there is no employee who is existing. So it will violate the rule of primary key. That is why an insertion anomaly is caused whenever we have a big, or you can say huge, database where we are storing the details of each and everything. Now the second is deletion anomaly. Now it occurs when we delete data, it removes the other valuable data. So consider that if we are deleting the data of any of the employee, it removes the other valuable data which we need for new set of employees who are joining the company. So consider that right now all the employees have left the company. So what it will do is, it will delete the entire data which is present for all the employees. Now it has deleted the entire data. But wait a second, while deleting the entire data, we are somehow losing the data of department, manager and salary, because we have deleted all the data which was present in our table. Now we don't know that what is the department, what is the manager of that particular department, and what is the salary, because we don't have any other table where we have the details of department, the manager who is of that particular department, and the salary details. So somehow while deleting the data which is present in the table, we are losing the set of valuable data which we require. Because consider that there is a new employee who has just joined the company. Now for that particular employee, I know the name, age and department, but I don't know the details of manager and salary, because it was present for the earlier employees. But for that particular employees, I have already deleted the data which was present. So I won't be knowing that if the person has joined the HR department, who is the manager and who is the salary. So whenever we delete data, it removes the other valuable data. So consider if you delete all the record in the table, you will lose the track of department, their manager and salaries. Now the third anomaly is updation anomaly. It occurs when changes to data require multiple updates. So whenever we are changing any set of data and it requires multiple updates to be done, because that particular data is present at multiple places. So whenever we are changing any data that require multiple updates, then the updation anomaly happens. Consider you want to change the salary for people who are working in HR department. You need to update it at 3 places. So here you can see that there are 3 people who are working in the HR department, and for now the people who are working in HR department have got an increment, and now their salary is been increased to 1200. Now we want to update at all the places where the HR department is present with this salary. But right now we are only dealing with data of 5 employees. But in general or in real life scenario, there are always a bunch of employees who work in a company. So whenever you want to update the salary of employees who are working in HR department, it will require a lot of effort, because that particular data would be present for a lot of employees who are working. And consider that by any chance you miss to update salary of one of the employees, so it will show incorrect data, that is data inconsistency would be there. So it leads to updation anomaly. Basically we have to do multiple updates of the data where the data is getting changed. So that is why updation anomaly happens. So how normalization help us here? Using normalization, we can divide the employee table into two tables. First table is employee table and the second table is department table. So let's see from here. Here you can see that department, manager and salary is something which is getting repeated for each and every employee. So what we did was we broke the table into two sub tables. So the first table would be having details such as employee ID, employee name, age and department. And the second table would be having details such as employee department, employee manager and employee salary. So let's see. So here we are having two tables, employee table and department table, wherein employee table is having details such as employee ID, name, age and department. And now from this we can identify that which department the employee is, and from the department table we can fetch in the details such as department name, department manager and department salary. So we have broke the table into two parts so that we can reduce the redundancy or data inconsistency which is being occurred. Now the first question which would be coming to your mind is, here also in the department column we are seeing duplicacy. The IT department is getting duplicated 2 times. The HR department is getting duplicated 3 times. Now normalization doesn't guarantee you to remove the entire duplicacy or entire data redundancy. What it says is it will lower down or it will reduce the data redundancy or duplicacy which is present in the table. So normalization doesn't guarantee you to remove the entire duplicacy, but it guarantees you to reduce the duplicacy or the redundancy which we have. Now here you can see that the duplicacy is being reduced because now I just need to provide a department name for any of the person who is joining my company. So let's see about all the 3 anomalies we discussed, how normalization is helping us to reduce the insertion anomaly, deletion anomaly and updation anomaly. Now consider that if there is a new employee who joined my company, so I can fill in the details of employee ID, employee name, employee age, and for now I can keep the department as null, and whenever the employee is assigned any department, all the department details is present here. So there is no duplicacy which is present for the employee, there is no null values which are being given to the primary key which is present here. We are only giving the department as null because right now I don't know which department the employee belongs to, but whenever the employee is assigned a department, I'll just fill in the department details, and from this particular table I'll get all the details of the department in which the new employee would be working. So insertion anomaly is reduced here. Now coming to the deletion anomaly, consider that you are deleting all the data which is present in our table, but still you have all the valuable information which you want because department table is still there. So you can know that if a person is in IT department, which is the manager and what is the salary of that particular person. Even if you delete the entire record which is present in the employee table, still you sustain the department information or the valuable information which is present there. So deletion anomaly is also taken care or reduced. Now coming to the third, that is updation anomaly. So consider that if you want to update the salary of the HR people, you just need to go to this department table and you just need to update it here. So there is a only single update which you need to do. Earlier you need to do it at multiple places because it was present in this particular table, but now since it is divided into 2 tables, you just need to update it at one place and it will start reflecting for each and every employee. Now coming to the types of normalization, so basically there are 3 types of normalization. The very first is first normal form or 1NF, then second normal form and the third normal form. The BCNF or Boyce Code normal form is an advanced version of the third normal form. So we would be learning about each and every normal form in detail. We will understand that how these normal forms are helping us to reduce the data redundancy. So in simple terms, you can say normalization help us to reduce the data redundancy or duplicacy which is present in our data. It doesn't guarantees to remove the entire duplicacy or redundancy of data, but it guarantees to reduce the redundancy which is present in our data. So what is this denormalization? This is the opposite of normalization. So whatever things we do in normalization, we just do the opposite in denormalization. It involves intentionally introducing some redundancy into a well-normalized database schema to improve query performance. Now in normalization, what we used to do is we used to reduce the data redundancy which is present in our table. Consider that there is a table of employee which is having employee ID, employee name, employee age, as well as this department details such as employee department name, department ID, department salary. Now in this particular table, we used to encounter some data redundancy or duplicacy because of rows as well as column. So row level duplicacy was make sure introducing the concept of primary key. We used to make an attribute such as ID as primary key, and now there couldn't be any null or duplicate values which is present in our ID column. So row level duplicacy was reduced. Now for column level duplicacy, we encountered that there were some columns which are having the same details like the department manager and salary whenever there is a IT department, and whenever there is a HR department, it used to remain same for the set of employees who are having the same department. Now for that, what we used to do is we used to normalize the table, and we used to break the table into two subtables or more tables so that we can reduce the column level duplicacy which we were encountering. But in denormalization, what it says is we intentionally introduce some redundancy into a well-normalized database schema to improve the query performance. Now in normalization, we used to break the tables into subtables, two or more tables. So this was the earlier table which was present. Now there are subtables to reduce the data redundancy. Now this is an employee table, this is the department table, and this is the salary table. Consider I want the detail of an employee who is having ID as 2, and I want the details of its department as well as its salary. So I want all the employee details, I want all the department details, I want all the salary details for an employee who is having ID as 2. Now for that, I have to make query into this particular table, and this table as well. And as the table increase, the queries also increase. Now we have to make different type of joins to get some data from the department as well as salary table. So because of that, our query is not very much optimized, or it takes a lot of time to fetch from each and every table, because there could be a possibility that the data is present at the very last of department table, the data is present at the very first of salary table, and because of that we encounter some issues like the query is taking a lot of time. Now the query, if it's being used in an API, the API is taking a lot of time, our SLAs increase. So because of that, we can encounter some time issues, some speed issues, and much more things. So because of that, we introduce the concept of denormalization, that we are intentionally introducing redundancy, but if all the data is present into the same table, the query time would be very less. So consider if you wish to find the salary of Rahul. So to find the salary of Rahul, first we need to find the department of Rahul. So first we have to make the query into the employee table to find the department. And once we get the department of Rahul, that is IT, then again we have to make a query in this department table to fetch the salary of Rahul. So you can see that we are making multiple queries. So multiple queries can increase the time, can reduce the speed, and our API can take a lot of time to provide us the result. So what are the benefits of denormalization? First one is faster queries. So it can reduce the need for complex joins between tables during queries, which can eventually improve the speed of retrieving the data, and it can give the data very fast. Now the second benefit is the queries would be simpler because there are no joins which are being involved. There are no 3 or 4 tables in which we are making queries. So the queries would be very less complex. It can simplify the queries by allowing them to be executed on a single table instead of requiring joins across multiple tables. So in normalization, we used to break a single table into multiple tables. Now we need to make queries into these tables. So because of making queries into different tables, the time also increases and the queries also get complex. In denormalization, we used to combine all the tables into a single table, even if we know that the data redundancy can occur, but still we are combining it into a single table, and because we are combining it into a single table, the time always reduces and the queries are also simple, so there are not complex queries. Now with advantages, there are always disadvantages. So let's see the disadvantages. So first disadvantage is increase data redundancy. As I told that we introduced the concept of normalization to decrease the data redundancy. But since in denormalization, we are again combining all the table into a single table, which is we are breaking the normalized table into a denormalized table. So we can say that the data redundancy has increased. Now the second is less data consistency, because if we are combining everything in a single table, consider that if I need to update the salary of a person who is working in IT department, and if somehow I miss to update for any of the employee, the salary would be different for both employees who are working in IT department. So that would be a data inconsistency. Now the third is denormalization can make the database schema less flexible for future changes like adding, modifying new data elements. So we learnt about the insertion, updation and deletion anomalies. So that can occur because of denormalization. We can't go ahead and add any of the data of any of the new employee who has joined the company, because right now I don't know the department manager and salary details of that particular employee. Or consider that there is a new department, supply chain, which is introduced in our company. For now there are no employees who are present in supply chain, and since ID is a primary key, we can't make it as null and we need to insert a data, but right now we don't have any data. So these type of issues can happen whenever we denormalize the table, but the only advantage is it makes the queries faster and it simplifies the query. Now, as the term suggests, functional dependency. So whenever there is a kind of dependency which is present in form of any function, we can call it as functional dependency. You might have heard about the terms such as equations or functions in maths. Now, if there is a function given y equals to fx, that is y is a function of x, where fx is equal to x square plus 2x plus 1. So if I know the value of x, I can determine the value of y. So what I'll do, I'll just put the value of x here. So that would be 1 plus 2 plus 1, that is 4. So here, if I know the value of x, I can determine the value of y. So y is a function of x, so we can say that y is functionally dependent on x, because whenever we know the value of x, we can find the value of y. Now in functional dependency, it describes the relationship between the attributes in a relation. So attributes you can say as columns and relations you can say as table. So whenever there is a table, consider that this is the table name is R, or we can say it is a relation where we have two attributes x and y, we can say columns. So if y is functionally dependent on x, it means if I know the value of x, I can determine or find the value of y. So a functional dependency is a constraint between two set of attributes in a relation from a database. So it's not important that it will always happen between single attributes. There could be a set of attributes which could be functionally dependent on some set of attribute. So consider that in a table there is a primary key. Now primary key can either be a single attribute or can be a set of attribute. So if roll number is something which is being repeated for each or every person in a combined branch like CSE, EC, so there could be a possibility that in CSE also a person is roll number 1. In EC branch also there is a person with roll number 1. So what we will do is we will take a composite attribute, we will combine two attributes to make it as a primary key or a unique identification key, using which we can find the details of that particular person or that particular student in a college. Now for a relation table R, if there are two attributes x and y, then we can say the functional dependency is x determines y, or we can say y is functionally dependent on x, where y is called as dependent and x is called as determinant. So x is called as determinant because if we know the value of x, we can determine the value of y, and y is somehow dependent on the value of x. So if I know the value of x, I can find the value of y. Consider in a normal table that if there is a roll number and there is a name. So if I know the roll number of any person, I can tell the name of that particular person. So roll number is kind of a determinant and name is kind of a dependent, and name is functionally dependent on roll number, because if I know the value of roll number, I can determine the value of name. So attribute y is functionally dependent on attribute x. So y is functionally dependent on attribute x, or we can say x determine y. Now, if x is equal to 1, we can find the value of y. The same example which I show here, that if we know the value of x, we can find the value of y here as well. Now, functional dependency x determines y. X, y is a subset of the relation. So, if there is a table or there is a relation, then x and y is always a subset of that particular relation. Here I am talking about subset, but what subset exactly is? So let there be two sets A and B. Now A is having value 1, 2 and 3 and B is having value 1, 2, 3, 4 and 5. Now A is a subset of B because every element of A is also an element of B. So we can say that A is a subset of B because every element of A, 1 is also present here, 2 is also present here, 3 3 is also present here. So A is a subset of B because all the elements which is present in A is also present in B. But vice versa is not true because 4 and 5 is not present in A. So we can say that A is a subset of B because every element of A is an element in B. Now here there is a table employee ID, employee first name and employee last name. So here there are some of the functional dependency which is provided. So first is that employee ID will always determine employee first name. So let's see if employee ID can determine employee first name. So if I know the employee ID as 1, is there any employee ID with 1 existing in this particular relation? No. Now in correspondence to 1, what is the employee first name? That is Riti. So if I know the employee ID, I can know the employee first name. So we can say that employee first name is functionally dependent on employee ID, or if I know the employee ID, I can find the employee first name. So you can also say that in functional dependency, the X is kind of a unique identification key. Unique identification key. So basically this is a unique identification key which help us to identify or determine or find the value of Y when we know the value of X. So for this employee ID also there is no 2 which is present in this particular column. So the value would be Rahul. For 3 there is no 3 which is present in this employee ID column. So we can say the value would be Suraj. So we can say that employee ID is determining employee first name, or employee first name is functionally dependent on employee ID. So employee first name is functionally dependent on employee ID. In the same way, employee last name is also functionally dependent on employee ID. Now here you will say that you have written the functional dependency, but how will we identify that if there is a table or there is a relation, what are the functional dependency which are existing? So the first way to determine that is that if there is X which is determining Y, X can always be a set of attributes and Y can also be a set of attributes. So we can also say that employee ID and employee first name both are determining employee last name. So X would be this set of attribute which is employee ID and employee first name. In the same way, we can also say that employee ID is determining employee first name and employee last name. So here Y is also a set of attribute. So this thing first we need to understand that X determining Y, X can always be a set of attribute and Y also can always be a set of attribute. Now how we will know the functional dependency in a given table? Now according to functional dependency definition, if there is a relation R, X determines Y, where X and Y are the attributes of the relation, and X can be an attribute or a set of attribute, Y can also be an attribute or a set of attribute, and Y is functionally dependent on X. Now here, can you say that X or the one which is a determinant is always a primary key? So can we say that X is a primary key? The answer is no. It's not always true that X will always be a primary key. This is a unique identification key, but it's not a primary key. It can be a primary key, but it's not important for X to be a primary key. It should always be a unique identification key. Now, how do we find that if there is a X which is present or if there is an attribute which is present is acting as a determinant or not? So as I told that it is not always true that it will always be a primary key. So there could be a possibility that there is some duplicacy in this employee ID column. So again, the employee ID is 1, the name is considered Ria and the last name is Singh. So here you can see now employee ID is having 2 ones which is present in the table. So it is not unique. So primary key violation happens because this particular employee ID or this particular attribute doesn't have unique values. Now if we want to now see that if this employee ID determines employee first name is true or not for this particular table, what we need to do is if there are 2 tuples or you can say 2 records and the value of X is similar for both of the records, then the value of Y should always be similar so that these are functionally dependent. So if there are 2 tuples T1 and T2, and if T1.x is equal to T2.x, that is this is equal to this, then T1.y should always be equal to T2.y for the functional dependency to exist. So let's see, is T1.x equal to T2.x? 1 is equal to 1. So this is true. So let's see if t1.y is equal to t2.y or not. So t1.y is Riti and t2.y is Riya. So is t1.y equal to t2.y? No. So now we can't say that employee ID determines employee first name, because consider that if I provide the employee ID 1, what would be the value of y it will return? Because right now 1 is having the value as Riti and 1 is also having the value as Riya. So now employee ID is not determining employee first name. But what if here the value is written as Riti? So now is the employee ID determining the employee first name? Yes, because 1 is always corresponding to only one value. 1 is not corresponding to two values. 1 is always corresponding to only one value. So this is the criteria which we use to follow to find the functional dependencies which are present in our relation. So if there are two tuples who are having the same value, such as like the same record is present in that particular two tuples, then we should always check the value which is being determined or which is functionally dependent on that value. So if there is employee ID which is having values such as 1 and 1, then we need to check that what is the corresponding value to this one, because there could be a possibility that this one is giving me Riti and this one is giving me Riya. So 1 is having multiple values. 1 should always hold single value because this is a unique identification. If I say that 1 is also giving me Riti, 1 is also giving me Riya, so the unique identification does not exist. X shouldn't be a primary key. It can or it cannot be, but X should always be a unique identification. So this is called as functional dependency. So whenever we encounter that if there is an employee ID column which is having unique values or where there is a primary key, we don't need to check for all those things, because if it's a primary key, it will always determine some unique values only. But if there are some duplicacy which is present in this employee ID, then we need to check this condition that for given two tuples, if the value of X is similar, the value of Y should always be similar. If it's not similar, then it's not functionally dependent or the functional dependency does not exist. I know this can be a bit confusing, but when we will learn about normal forms, that would be clear more and more. For now, you can just understand that in functional dependency, there is a relation and then there are some attributes. One attribute is functionally dependent on another attribute. It basically means that if I know the value of X, I can determine the value of Y. X and Y can be a set of attributes. X is not always needed to be a primary key. It can or it won't be, but X should always be a unique identification key. That is, for one value of X, there should always be one value of Y. There shouldn't be a multiple values of Y. Now there are some properties of functional dependency, or we can also call it as inference rules. Now what are those properties? So the very first property is reflexivity. Now what is this reflexivity? So if there are two attributes X and Y, where Y is functionally dependent on X and X determines Y, we can say that if Y is a subset of X, then X determines Y or X determines X. Now how this comes X determines X? So here I told that Y is a subset of X. So Y is always having some values which is present in X. So Y will always have the value X. So we can say that X determines X. So a particular attribute can always determine itself, and it can determine Y if Y is a subset of X. So X determines X always holds true in terms of the reflexivity property. Because Y is a subset of X, so Y would always be having values which are having X. So X determines X always holds true. Now the second property is augmentation. What does this mean? That if X determines Y and if we are augmenting Z here, then XZ should always determine YZ for any Z. So consider that there is an employee ID which determines employee name. Now if I augment or add something, so if employee ID, I add an employee phone number. So employee ID, employee phone number both together can determine employee name and employee phone number. So I can see that if something is added at LHS and the same thing is added at RHS, then there would be a functional dependency which will exist between this combination. Now the third one is transitivity. So what this transitivity says us, if X determines Y, so if X is an attribute which determines Y and then Y is an attribute which determines Z, then X is an attribute which will always determine Z. So if X determines Y and y determines z, then x will always determine z. We don't need to check for this dependency if this exists or not. If x is a attribute which determines y and y is an attribute which determines z, then we can say that x will determine z as y is common between them. So this is called as transitivity. Now the fourth one is union. Now what union says is, if x determines y and x determines z, since LHS is common in both the cases, we can say that x will determine yz. So since x determines y, x also determines z. So since employee ID determines the employee first name and employee ID determines the employee last name, then we can say that employee ID can determine employee first name as well as employee last name. So there is a union which happens whenever the LHS is equal. But the vice versa is not true. If I say yz determines x, I can't say that y will determine x and z will determine x. This is wrong, because again, yz is something which is a combination which is helping me for the unique identification, or this is a unique identifier or a key. So if the both of these key are helping me to determine one attribute, I can't say that a single attribute can determine this particular attribute, because the composite version of this is helping me to determine the attribute. So if x determines y and x determines z, we can say that x determines yz, but we can't say that if yz determines x, y will determine x and z will also determine x. That is wrong and that is not true. Now the fifth rule is rule of decomposition. So if x determines yz, we can say that x determines y and x determines z, which is the same which we learnt in union. So it's just the reverse of union. So if x determines yz, we can say x determines y and x determines z. So the determinant can never be broken. Determinant can never be broken. If it's a set of attributes, it can't be broken into single attributes and determine something, because the set of attribute is helping in the unique identification, not the single attributes, right? So this can't be broken. The RHS can be broken. The dependent can be broken, but the determinant can't be broken. Now, what are the types of functional dependency? So there are two types of functional dependency. One is trivial and the second one is non-trivial. There are more, but basically now we need to know about these two only, trivial and non-trivial. So let's see what is trivial. So functional dependency x determines y is trivial if y is a subset of x. So it says that if y is a subset of x, x can determine y and x can also determine itself, that is x. So this particular dependency is always valid. We don't need to go ahead and check in our table, because x can always determine x. Employee ID can always determine employee ID. If I say that employee ID is 1, find the employee ID in the table, I can always find the employee ID because I know the employee ID is 1 here. So x will always determine x. This is a valid dependency. This doesn't need to check that if there are some employee IDs which are present, if again there are some employee IDs which are present, because we are seeing in the same column, or you can say in the same attribute itself. Also, since y is a subset of x, y will be having values or the elements which is present in x. So we can say x will determine x. So we can also say it as x determines x. Now consider that here there is a dependency given where employee ID and employee first name is determining employee ID. Now this is y and this is x. Now in y we have employee ID and in x also we have employee ID. So we can say that y is a subset of x because the element which is present in y is also present in x. So we can also say that employee ID determines employee ID. And employee ID, employee first name determines employee ID. Now, this is trivial because employee ID is a subset of employee ID and employee first name. So, we can say that trivial dependency exists whenever x intersection y is always y. So, whenever we are doing an intersection between them. So, we are doing an intersection between employee ID and employee first name. So in intersection, we used to provide the common which is present between them. So in employee ID and employee first name, employee ID is the common one. So we give the value as employee ID for a result. So x intersection y always gives us y. Y is employee ID. So here we get the employee ID. So this is the trivial dependency. Now, what is non-trivial dependency? A functional dependency x determined y is non-trivial if y is not a subset of x. So, y is not a subset of x, basically, which means that if there are some values which is present in y, or if there are some attributes which is present in y, it's not necessary for that attributes to be present in x. So here if you can see, x is having employee name and y is having employee ID. So employee ID is not present in employee name, so y is not a subset of x. So these dependency needs to be proved, because so right now I am saying that employee ID is getting determined by employee name, or employee ID is dependent on employee name. But is this true? Like, we have to check that if this is valid or not. In trivial, what used to happen is x determines y and y is always a subset of x. So y always contains some element which is there in x, or y is always having some attributes which is in x. So this is always true. But when x determines y and y is not a subset of x, then we need to prove that point ki, okay, if employee name is determining employee ID, I can check from my table if this functional dependency is present or not present. So a functional dependency x determines y is not trivial when the y is not a subset of x. So if there is x as employee ID and y as employee first name, we can say it is non-trivial because employee first name is not a subset of employee ID. So employee first name does not have any element which is there in employee ID. So here if we do x intersection y, we get 5, because x intersection y does not gives us anything, because there is nothing common between employee first name and employee ID. So it will give me 5 or it will give me empty. Now what is this attribute closure or closure set? As the name suggests that it will give me a set of attribute. But what is it exactly? So let's see. Attribute closure help us for identifying candidate keys, checking for functional dependencies, and in normalization. So whenever we need any kind of help in finding the candidate keys which is present in our relation or the super keys, and whenever we need any help in checking the functional dependencies present in our table, we use the attribute closure. So whenever there is an attribute x, it can be an attribute, or you can also call it as a set of attribute. So whenever there is an attribute or a set of attribute, the closure set of this particular attribute is denoted by the plus sign, and it gives me the set of all the attributes which can be determined by this particular attribute x. So closure of any attribute is denoted by plus sign, and it gives me all the attributes which are present in the relation which can be determined by x. So here x is an attribute or set of attribute which gives me all the attributes in a relation which can be determined by x. So consider that there is a relation in which there is a functional dependencies x determine A, and there is one more functional dependency x determine B. So since x is determining A and x is determining B, if I find the closure of x according to the definition, it should give me all the attributes which can be determined by x. So that would be A and B. So A and B would be the closure set of x. So x closure gives me all the attributes which is present in the relation which can be determined by x. So let's see a practice question on how we can determine the attribute closure or closure set on some of the attributes which is present in a relation. So consider we have a relation R with attributes such as A, B, C, D and E. And there are some functional dependencies which are given as such. A determines B, B determines C, C determines D and D determines E. Now this A determines B says that if we know the value of A, we can find the value of B, or B is functionally dependent on A. So these all things are being taught in the functional dependency video. So if you're not understanding this, you can go ahead and watch that video first and then come to this video. Now, how we can find the closure set of some of the attributes which is present in this table? So let's see. So the very first step is, now according to the rule of reflexivity, all the attributes can determine their self. So according to the rule of reflexivity, it says if y is a subset of x, then x can determine y. So since y is a subset of x, y would always have all the elements which is present in x. So we can also say that x can determine x. We can replace y with x because y would be having all the elements which is present in x. So we'll just use the rule of reflexivity and derive some of the functional dependencies, that is A will determine A, B will determine B, C will determine C, D will determine D, and E will determine E. So all the attributes can determine themselves according to the rule of reflexivity. Now the second step is, now according to the rule of transitivity, if A determines B and B determines C, then we can say that A can also determine C as B is common between them. So whenever A determines B and then B is an attribute which determines any other attributes, then A can also determine C. So since in the question we have some of the functional dependencies present, so let's use this functional dependency and let's use the rule of transitivity to derive some more functional dependency which will be helpful for us to find the closure. So let's see for A. So here it is given A determines B and then B determines C. So since B is common between them, can we say with the rule of transitivity that A will determine C? Yes, we can say. So the first functional dependency which we derive is A determines C. Now B is determining C and C is determining D. Now C is again common between them. So we can say B will determine D. So B will determine D is the second dependency. Now C determines D and D determines E. Again D is common between them. So we can say that C will determine E. So C will determine E is the third dependency which we got. Now since we have got 3 new functional dependency and these are also existing. So let's see if there are more dependencies which can come. So since here we can see that A determines C and here is there any C present? Yeah, C determines D. So we can say A determines C and C determine D. Since C is common between them, then A will determine D. So A determine D is another dependency. Now since A determines D, let's see that if there is any functional dependency with D. Yes. So D determines E. So we can say that A determines D, D determines E. So A will determine E. So A determine E is also a functional dependency. Now here E is present. So is E determining any of the dependency? No. So these will be all the dependencies of A. Now coming to B. So B determine D. Is there any D determining any of the attribute? Yes. So D determines E. So we can say since D is common between them, B determines E. Now coming to E, is there any E which is determining anything? No. So these will be the dependencies of B. Now coming to C. So C determines E and since E doesn't determine any of the attributes, so this will be the only functional dependency for C. Now coming to the third step, now according to the rule of union, if the determinant is same, we can combine the dependent. So according to the rule of union, if X determines A and X determines B, we can combine the dependent since the determinant is same. So we can say X will determine AB. So since we have all the functional dependencies with us using the rule of reflexivity and transitivity, let's see that how we can find the union. So for A, since A determine B, A determine C, A determine D and A determine E using transitivity rule and A determine A using reflexivity rule. So A will determine all A, B, C, D, E. In the same way we find for B, C, D and E. So B will determine C, D, E, B, C will determine D, E, C, D will determine ED and E will determine only E. So here the position doesn't matter. We can also write it as B, A, C, E, D. Like in any manner we can write. It's just that all the dependents should be present. So this step 4 is we have to find the closure set of attribute. So what it says is whenever we are finding closure of any of the attribute or the set of attribute, it contains all the attributes or all the set of attributes which can be determined by the attribute for which we are finding the closure. So here A closure will contain all the attributes which can be determined by A. So since here we have find all the functional dependencies and here we have find all the attributes which can be determined by A. So here you can say A can determine A, B, C, D and E. So A closure will have A, B, C, D and E as mentioned here. So A closure will be having A, B, C, D, E. In the same way B closure will be having this, C closure, D closure, E closure. So here you can see that we are finding the closure of set of attribute. So whenever we need to find the closure of set of attribute, what we do is firstly we write all the attributes which can be determined by A. So that is A, B, C, D and E. And then we write all the attributes which can be determined by B. That is B, C, D, E. But that is already present in the set, so we don't need to duplicate or repeat it. So this is the attribute closure of AB plus. It will be having all the attributes which is present in the relation. So it will give me all the attributes which can be determined by A, then all the attributes which can be determined by B. So combined it gives me A, B, C, D and E. Now, since we learnt about attribute closure in the last video, we would be using that attribute closure and finding super keys in our given relation or in our given table. Now, let's find the candidate key, super key, prime and non-prime attributes. So, what is super key? Super key is a set of attributes whose closure contains all the attributes given in a relation. So basically, super key is attribute, or you can say a set of attribute. So X is a super key. It can be a single attribute or it can be a set of attribute whose closure contains all the attributes which are given in a relation. So consider that there is a relation or there is a table. In that particular table, attributes basically means the columns. So consider that there are 3 columns, A, B and C. And if the closure of X contains all A, B and C, then this is qualified to be a super key. So whenever a closure of any of the attribute or set of attribute contains all the attributes which is present in a relation, we can call that attribute or set of attribute a super key. Now, a key combination of all possible attributes which can uniquely identify 2 tuples. So super key is also a key which can uniquely identify 2 tuples. A key can be a combination of attributes or can be an attribute. Now, how to find the super key? So there are certain steps which we need to follow to find the super key. So let's see. So the very first step is we have to identify all the attributes. So the first step is identify all the attributes which is present in our table. So consider that right now it's A, B and C. So we have identified all the attributes. Now the second is we have to analyze the functional dependencies and find the closure. So how we used to find the closure is, consider that if we are finding a closure of A, so we have to see that what all attributes does A determines. So consider that A determines B, A determines C, A determines D. So closure of A would contain B, C, D, and from the reflexivity property, A can also determine itself. Because according to the rule of reflexivity, an attribute can determine Y whenever Y is a subset of X. So what does this mean? Y is a subset of X. Basically, Y will have all the elements which is present in X. So can we replace this Y with X here? Yes, we can do. So we can say that an attribute can determine itself using the reflexivity property. So A can determine E. So we can say the closure of A contains all the attributes which is present in our table. So this can possibly be a super key. So we have to analyze the functional dependencies like A determines B, B determines C, C determines D, any of the functional dependency, and then we have to find the closure. Now we have to generate the power set. So right now I am saying that A is my super key, but super key can be an attribute or can be a set of attribute. So AB can also possibly be a super key, AC can also be a super key, consider BC can also be a super key. So we need to find out that what all attributes or set of attributes can be the super key. So for that we generate the power set. In that power set we get all the attributes or all the possible combinations which can be of super key, and then we determine that if that possible combinations closure is giving me all the attributes which is present in the relation or not. So if it's not giving, it's not a super key. If it's giving, then it's a super key. So if A has n attributes, the power set of n will be having 2 to the power n subsets. So consider that here X is having 3 attributes. So what would be the power set of X? So that would be 2 to the power 3, that is 8. So power set of X would be having total 8 sets. So total 8 combinations, and in that combinations we can check that which particular combination or which particular single attribute qualifies to be a super key. Then the final check is check for super key property. So we have to check for the super key property. So from here we have generated all the subset. Consider a subset A, B, C, we can say AB, AC, BC. We have generated all the power subsets. Now for these power subsets, we have to take the closure of all these power subsets, and we have to see that if the closure determines all the attribute, or if in the closure all the attributes are present which is there in a relation. If it is there, then that particular set can be a super key. If it's not present, then we will discard this from the final result. So for each subset in the power set, check if it can uniquely identify each tuple in the relation. So let's solve a practice question where we will be finding all the super keys. So here the relation is given as R, A, B, C, and the functional dependencies are given as A determines B and B determines C. So these are the functional dependencies which are provided. And this is the relation which is provided along with all the attributes. So what was our step 1? We have to identify all the attributes. So to identify all the attributes, we can see that there are 3 attributes in a relation. So we will just note it down: A, B and C. So in step 2, we have to analyze the functional dependencies and find the closure. So here you can see that we have been provided with 2 functional dependencies: A determine B and B determine C. So this is provided. Let's derive some of the functional dependency. So since A determines B and B determines C, can we say since B is common between them, A will determine C from the property of transitivity? So we can say that A will determine C is a property which we have derived, or is a functional dependency which we have derived. Now we have derived A determines C. Now each attribute can determine themselves. So we can also say A will determine A, B will determine B and C will determine C. Apart from that, we can't find any other functional dependency. So these are the functional dependency which we have calculated, and these were the provided ones. Now from this functional dependency, if we find the closure of A, we have to write down all the attributes which A determines. So A can determine C, so we will write C. A can determine A, so we will write A. And A can also determine B, so we will write B. So the closure of A will contain C, A, B. So here you can see that A closure has C, A, B, which is also the attributes which is present in our relation. So can we say that A is a super key? Yes, we can say that A is a super key because A closure determines all the attributes which is present in our table, that is A, B and C. Now B closure. So B closure will contain B and C, and it does not determine A, so there won't be any A, and C closure would be only having C. So B closure and C closure does not qualify to be a super key. This particular thing you can also do after the generation of power set, or you can do before the generation of power set. I'll tell you that why before the generation of power set this is useful. So the closure of A gives or determines all the attributes in the table, so we can say it's a super key. Now the third step is how do we find all the super keys? So for that we have to find the power subset. So we have to find the power set of A, B and C. So since I told that the power set of any of the given set is 2 to the power, consider that this set is x, so it's 2 to the power x. So here it will be 2 to the power 3, so here it will be 8. So the power set of this particular set would be having 8 elements. Now let's understand about power set. So power set is the set of all subsets of a given set, including the empty set as well as the set itself. So consider that there is a set x. X is having elements such as A and B. Now in this, if we calculate the power set of x, it will be having set of all subsets. So basically it will be having set of all subsets of A and B, including the empty set as well as the set itself. So set itself is AB, empty set is this which is having no element, and the subset will be A and B. So the power set of x equals to AB would be having these 4 elements. Now the power set of x is denoted by 2 to the power x. So we can see that the power set of x would be 2 to the power x, which is 2 to the power number of elements, that is 2 to the power 2, which is 4. Now let's see if there are 4. So 1, 2, 3 and 4. So the power set of x is having 4 sets. Now let's take a simple example, the same example which I explained above. So the power set of x would include the following subsets. One is the empty set, this one. One is the single element set, that is A and B. And one is the full set itself, that is AB. So the power set Px would be Px is equal to 5, which is an empty set. Then A, B and AB. In this way we can calculate the power set of any given set. So the power set of ABC would be having firstly 5, or you can say empty set. Then we will be having single elements, so A, B and C. Then we can have the combination, so we can say AB, AC, then BC, and then we can say the entire set itself, so that would be A, B and C. So here you can calculate that there are 3 elements, so it will be having 2 to the power 3, that is 8 sets. So if we calculate here, so 1, 2, 3, 4, 5, 6, 7, 8. So we have got 8 sets overall. Now to calculate all the super keys, what we will do is we will take the closure of all those 8 sets. So let's take a closure. So first is this empty set. So the closure of empty set wouldn't give anything, so it's not a super key. Second, A, we calculated that A is a super key after taking the A closure. So we can say that it is a super key as its closure determines all the attributes in a relation. Now the second is B. For B also we calculated that B doesn't determine A. So B does not have all the attributes which is getting determined in the relation. So B is not a super key. Again C. C only have C in the closure. So C is not also a super key. Now the next is AB. So for AB, do you need to determine the closure and then conclude that it is a super key or not? If you remember, in the first step, we calculate the closure of the single attributes, that was A, B and C. And from that we found out that A is a super key, B and C were not a super keys. So since A is a super key, can we say that if any attribute is augmented with A, that will also be a super key? Because if I take a closure of AB, A closure will only contain all the attribute which is present in the relation. So if we augment anything with A, that will also be a super key, right? Let's take a closure of AB. So if we take a closure of AB, we can say that A determines A, B and C, and B will determine B and C, which is already present here. So we can say that if anything is augmented with a super key, that also becomes a super key. So we can say that AB is a super key since A is already a super key. So adding B still keeps it a super key. So we can say AB is a super key. Now coming to AC, the same thing, that A is always a super key. So if we augment anything with A, that will also become a super key. So AC is also a super key since A is already a super key. So adding C still keeps it as a super key. Now coming to BC, neither B, neither C, both of them are not a super keys. So we have to take the closure and we have to find out that if the closure of them gives us a super key or not. So if we take the closure, B gives us B, C gives us C. B does not determine A, either C does not determine even B or C. So BC closure does not give me all the attribute which is present in our table. So we can say that BC is not a super key as B determines C but does not determine A. Now coming to A, B and C. Again, since A is already present here, if we augment anything with A, that will be a super key. So we can say it is a super key as A is already a super key. So adding B and C keeps it as a super key. So we can say that there are 4 super keys for the given relation, that is AB, AC, ABC and A. Now consider that right now we were dealing with only 3 attributes. So calculating the power set was easy, but consider that someone asked you to find the super keys for a given relation where there are n number of attributes. Would you go ahead and find the power set and then find the closure? It would be a very tedious task. So for that we have a formula. So to find the maximum number of super keys, we can use the formula which is 2 to the power n minus k, where k is the candidate key with k attributes. That is, considered that k is a key which is having a k number of attributes and it is a candidate key, and n is the total number of attributes in the given relation. So using this formula we can find out the number of super keys, but we should be knowing that what is the candidate key. So in the next video we would be learning on how we can find the candidate keys in a given table. After that you can use this formula to find the super key. When there is one candidate key, we can say that it is 2 to the power n minus 1 since k is the candidate key and there is only one key present here. So we can say it is 2 to the power n minus 1. When there are 2 candidate keys, so for the first candidate key it will be 2 to the power n minus 1. For the second candidate key it will be 2 to the power n minus 1. And then in these both candidate key there could be occurrence of both the candidate keys together. So for that we will be subtracting 2 to the power n minus 2. That is the combination of both the candidate keys. Now what is a candidate key? So a candidate key is basically a super key whose proper subset is not a super key. So let's understand term by term. What is a super key? So an attribute or a set of attribute is considered to be a super key if its closure gives all the attributes which is present in our relation. So consider that there is a relation or there is a table in which the attributes are A, B and C, and if the closure of a attribute or a set of attribute gives us all the attributes which is present in our relation, these are considered to be a super key. Now what is this proper subset? So consider that if we are having a set which is having elements such as A and B. Now if we want to take the subset of this, so it will be having phi, A, B and AB. In proper subset, what it says is it should have all the elements except the element for which the subset we are taking. So it should be having all the elements. It should be having phi or empty set. It should be having A. It should be having B. But it shouldn't be having S, that is AB. So if we are taking a proper subset of a given set A and B, it should be having individual A and B but not AB, because that is already present in S. So here we can say that proper subset of S is all the elements which is present in S except the elements which is present in the set S itself. So all the elements of A are also the elements of B. So all the elements of, consider that this is a set A. So all the elements of set A are also the elements of set B, and set B has at least one element that is not in A. So in A, if we take the subset of this, so it would be A, B, AB and phi. So at least AB, there is one set which is not there in B. So we can say that B is a proper subset of set A because B has at least one element that is there in set A but not in set B. So it has all the elements which are there in set A, but there is only one element which is there in set A but not in set B. So this is called as proper set. So we can say that whenever we are calculating the proper subset of a given set, it has all the elements which is present in the set except one element which is the set itself. So now coming back to the definition of candidate key. So it says a super key whose proper subset. So consider that AB is a super key right now, and the proper subset of AB is A, B and phi is not a super key. So how we can find the super key? We have to take the closure. So we will take the closure of all three, and if the closure of all three are not super keys, we can say that this is a candidate key. If any one of them tends to be a super key, we can't say that this is a candidate key. So first we have to find out the super key, then we have to take the proper subset of super key, then we have to find that if the proper subset is a super key or not. So for that we will take the closure, and when we take the closure we will know that if it is determining all the attributes of a given table, and if it's not determining, we can say that this particular is not a super key, and if it's determining, we can say that this is a super key. And if any one of the proper subset is a super key, we can say that AB is not a candidate key. I know it might sound confusing, but let's see from a practice problem, and then you will get a clarity on how we can find out the super key and the candidate key in a given relation. Now, there are two things you need to know before proceeding ahead with finding the candidate key. First is prime attribute and second is non-prime attribute. Let's see what are these. So an attribute that is a part of candidate key, we call it as prime attribute. So consider for now AB is our candidate key, and in our relation there are three attributes A, B and C. So we can say that A and B are the prime attributes as they are part of candidate key. And non-prime attribute are an attribute that is not a part of candidate key. So since there were three attributes and two of the attributes were part of candidate key, so we can see that C is a non-prime attribute and A and B are the prime attributes, since A and B are there in candidate key and C is not there in candidate. So how we can find the number of candidate key? Here are some steps we should follow to find the candidate keys. So the very first step is we have to take the closure of the entire attribute set. So consider that in our relation there are three attributes A, B and C. So what we will do is first we will take the closure of the entire attribute set. Now secondly, we will discard the dependents if the determinants are present. So what are dependents and determinants? Consider that there is a functional dependency A determines B. So we can say since A is determining B, this is determinant. And since B is functionally dependent on A, we can say that this is dependent. So in step B, what we have to do is we have to discard the dependents if their determinants are present. So since B's determinant is A and A is already present here, so what we will do is we will discard B from here. So we will discard the dependents if their determinants are present. Now after discarding, the final combination you get is a candidate key if its subset does not have a super key. So what we'll do is first we'll take the entire closure of all the attributes, and there we can find out that the closure will contain all the attribute of a given table because we are taking all the attributes closure, so it will be having all the attributes. So this is a super key. Now we have find out that there is a super key. From that super key, what we will do is we will go to the functional dependencies which are provided, and there we will see that if any dependent having a determinant is present here or not. If the determinant of any of the dependent is present, then we will discard the dependent. So here we have discarded B. Now we have left with AC. So can we say that AC is a candidate key? Right now, no, because we have to check if the proper subset of AC, that is A and C, is a super key or not. So what we will do here is we will take the closure of A, we will take the closure of C, and we will see that if it is a super key or not. If it's a super key, then we can say that this is not a candidate key if any of one of them is a super key. And if both of them are not a super key, we can say that AC is a candidate key. So right now we are assuming that AC is a candidate key. So we will mention A and C in the prime attribute. As the last step mention them in the prime attribute. Now in step 4, we will check that all the functional dependencies, and we will see in the right hand side if there is an attribute which has a determinant present in the prime attribute. If yes, mention that as well in the prime attribute and replace the dependent attribute with the determinant and check its candidate key. So right now we have found out that prime attributes are A and C. So we have to see that if A or C are lying in the right hand side of the functional dependency. So right now we have only one functional dependency where A determines B, and none of the prime attributes lies in the right hand side. But consider that if you have a dependency such as B determines C. So here you can see that C is a prime attribute and C lies in the right hand side. So what we can do is, right now we have calculated that AC is a candidate key. We can replace the dependent with its determinant. So right now AC is our candidate key. What we will do is, since C is the dependent and B is the determinant of C, we can replace C with B and we can check that if AB is a candidate key or not. So in this way we can find out all the combinations for which we can check that if they are candidate keys or not. If no prime attribute is available in the right hand side of functional dependency, we can say that there are no more candidate key, and the one key we made after discarding the dependent and checking for the super key is the only candidate key. So in this case, A and C and the functional dependency was A determines B. Since there were no dependents which were present in the right hand side which were in the prime attributes, we can say that only AC is the candidate key. But when we added some additional functional dependency where B determines C and C is a dependent, so we can replace the dependent with its determinant, where AC can be replaced by AD, where C is replaced by B, and we can find out that if AB is a candidate key or not. So let's solve a practice question where we will find the candidate as well as super key for a given relation R, A, B, C, D, and the functional dependencies are given as follows. So let me just write it here. So there is a relation R, A, B, C, and D, and the functional dependencies provided are A determines B, B determines C, C determines D, and B determines A. So let's see that how we can find the candidate as well as super key. So let's find the super key. So to find the super key, firstly we will identify all the attributes. So all the attributes present are A, B, C, and D. Now in the second step, we will analyze the functional dependencies. So we will analyze that A determines B, B determines C. From this we can say A will determine C. Now B determines C, C determines D. Since C is common, we can say B determines D. Now B also determines A, and A determines B, B determines A. So A determines A is also a functional dependency. This is also the rule of reflexivity. We can say B determines B, C determines C, and D determines D. These are all the functional dependency. Now what we will do is we will find the closure for the single attribute. So firstly we will find the closure for A, B, C, and D, and we will see that if they are super keys or not. So let's find. So firstly we will find the closure for A. So A closure will be having A, since A determines A. So we can say A closure will be having A for sure. Then A closure will be having B, since A is determining B. Now A is determining B, B is determining C. So A is also determining C. So we can say C is also there. Now A is determining B, B is determining C, C is determining D. So we can say B is determining D and A is determining B. So A is also determining D. So we can say D is also there. Now let's calculate for B. So B closure would be having B. Now B determines C. So let's write C. And C determines D. So we can say B will determine D. So we'll write D. And B also determines A. So we can write A. So the B closure will be having B, C, D, A. Now let's take the C closure. So C determines D, C will determine itself, and C will determine D. And then none of them. So C closure will be having C and D. Let's find the D closure. So D is determining nothing. So we can say D will determine only itself. So from here we can see that A closure and B closure are having all the attributes which are present in our relation or table. So we can say that A is also a super key and B is also a super key. Since C and D closure does not have all the attributes, so we are discarding them. So from here we got to know that A and B are super keys. Now we have to find the power set of this. So let's find the power set. So power set of A, B, C, D will be having 2 to the power 4, that is 16 sets. Now among that 16 sets, if there is any A which is in any set, that will be a super key. If there is B in any set, that will be a super key. So right now we will not go ahead and find the power set and then calculate the closure of that particular power set, and then we will find out the number of super keys. In the last video I told you about a formula where we find the number of super keys using 2 to the power n minus k, where n is the number of attributes and k is the attributes which is present in the candidate key. So if we find the candidate key, we can find the super key. And right now we know that A and B are at least a super key. Right now we don't know that if A, B, B, C, C, D are a super keys or not. But for now we know that A and B are the super keys. So let's find the candidate key. So for finding the candidate key, first we have to take the closure of the entire set. So we'll take the closure of the entire set, that is A, B, C, D. So A, B, C, D closure would be having A, B, C, D, because each attribute will determine itself using the rule of reflexivity. So we can say that this is a super key. So now in the step 2, we have to discard the dependents if the determinants are present. So we have got this key as A, B, C, D. Now in this we have to discard the dependents if the determinants are present. So the functional dependencies which are provided to us are A determines B, B determines C, C determines D, and B determines A. Now these are the functional dependencies which are provided to us. And also we can also say, using the rule of transitivity, A determines C and B determines D, since B is common between these two and C is common between these two. Now here we have to discard the dependents if the determinants are present. So let's start. So here B is the dependent and A is the determinant. Both are present, so we can discard the dependent, that is B. So now we are left with A, C and D. Now coming here, C is the dependent and B is the determinant. C is present but B is not present, so we will not take this into consideration. Coming here, D is the dependent and C is the determinant. C and D both are present, so we can discard the dependent, that is D. So we are left with AC. Now coming to this functional dependency, A is the dependent and B is the determinant, but since A is only present here, we will not look into this functional dependency. Now coming to this, C is the dependent and A is the determinant. A and C both are present here, so we can discard the dependent, that is C. Now coming to this functional dependency, B determines D. D is the dependent and B is the determinant. Any of the B and D is not present here, so we can ignore this. So after step 2, we are only left with A. Now, after discarding, the final combination you get is a candidate key if its subset does not have a super key. So we have to take the subset of A. So subset of A would be 5. Now 5 closure does not gives me anything, so this is not a super key. So we can say that A is a candidate key because the proper subset of A does not gives me a super key. So we can say A is the candidate key. Now what we have to do is we have to mention them in prime attribute. So we will make a prime attribute and here I can mention A. So in the fourth step, what we will do is we'll check for all functional dependency and see if in the right hand side there is an attribute which has a determinant present in the prime attribute. So what we have to do is in the right hand side we have to see that if A is present or not. If A is present, then mention at this in the prime attribute. So we have to mention that particular determinant in the prime attribute, and then we have to replace this dependent with that particular determinant and check if it's a candidate key or not. So what we have to do is we have to check in the right hand side if A is present or not. If A is present in right hand side of any of the functional dependency, we have to replace A with the determinant and we have to mention that in the prime attribute. So for now we can see that there is only one place where A is in the right hand side and there is a determinant of A, that is B. So what we will do is we will mention that in the prime attribute and then we will replace A with B and follow the same step and see that if it's a candidate key or not. So let's see. So let's take a proper subset of B. So the proper subset of B is 5. And if I take the closure of 5, this is not giving me a super key. So we can say that B is also a candidate key. So here B and A both are candidate key. Now for B, we have to see that if B is present at the right hand side of any of the functional dependency, yes, B is present in this functional dependency, but A already is a candidate key, we have already seen. So we have to do nothing because now B is not present in any of the functional dependency in the right hand side. So if no prime attribute is available in the right hand side of functional dependency, we can say that there are no more candidate key, and the one key we made after discarding the dependent and checking for the super key is the only candidate key. So right now we can say that A and B are the only candidate keys in this particular relation. So this is how we find the candidate key. So here we can see that there are two candidate keys. Now for super key, we have a formula 2 to the power n minus k, where n is the number of attributes and k is the number of attributes in the candidate key. So let's see that how we can find the number of super keys when we know the candidate key. So here the candidate key is A and B. Now if I calculate for A, I can say that it will be 2 to the power n minus k. So n is 4 and the number of attribute in candidate key is 1. So we can say it's 1. So it would be 2 to the power 3. Now coming for B, it will again be 2 to the power n minus k. So n is 4, number of attributes, that is A, B, C, D, and then k is 1 because we are only calculating for B. So it will be 2 to the power 4 minus 1, that is 2 to the power 3. So for A, we are having 2 to the power 3. For B, we are having 2 to the power 3. But consider that we are calculating for the combination where A, B both are there and both are the candidate keys. So what we will do is, when we are calculating for both of the combination, there is A, B, C, D, and here if I say that A and B both are candidate key, so only C, D can have a combination with A, B, because if A, B is present anywhere, that would be a super key, right? So we have to calculate only for C, D. So we can say that here, since two attributes are candidate key, so in 2 to the power n minus k, n will be 4, but the number of attributes which is present in candidate key is 2. So we can say it would be 2 to the power 4 minus 2, it would be 2 to the power 2. So we have to just subtract that. So it will be 2 to the power 2 minus. So it will be 8 plus 8 minus 4, that is 12. So we can say that this is having 12 super keys and 2 candidate keys. So in this way we find the super key as well as candidate key in a given relation. Now before starting with first normal form, let's just re-revise about normalization. So consider that there is a table. Now table would be having some rows as well as columns. There could be a possibility that some of the rows have duplicate values, or there could be a possibility that some of the columns also have duplicate values. So from this we can conclude that there are two levels of duplicacy. First is a row level duplicacy and second is a column level duplicacy in a given table. Now row level duplicacy can be eliminated using primary key. Primary key makes sure that there is a unique identifier which uniquely identify each row in a given table. So we can eliminate the row level duplicacy using primary key. Now coming to the column level duplicacy. So column level duplicacy is not eliminated using primary key. So what we do is we divide the table into two or more tables so that the column level duplicacy is reduced, and this is what normalization is. So normalization is basically division of a given table into two or more subtables so that we can reduce the data duplicacy, or you can say data redundancy, and also maintain the data consistency along all the tables. Now coming to the first normal form. So first normal form is the first step in the normalization process which help us to reduce the data redundancy. As I told that normalization is oftenly used to reduce the data redundancy, or you can say data duplicacy, and first normal form is the first step in the normalization process which help us to achieve that. Now what it says is every table should have atomic values, that is there shouldn't be any multi-valued attributes which is present in a table. Now what is this multi-valued attribute? So consider that there is an attribute or a column phone number. Now one given person can have multiple phone numbers, like I can also have 2 phone numbers or 3 phone numbers. So we can say that phone number can have multiple values. So we can say a given attribute, whenever it holds multiple values, that is a multi-valued attribute. So to ensure that a given table is in first normal form, these are some set of rules a given table should follow. So the first rule is atomicity, which says that attribute should always have single value. That is, there shouldn't be any multi-valued attribute which is present in our table. If in our table there is a multi-valued attribute, we can say that our table is not in first normal form. Now coming to the second set of rule, that is uniqueness of rows. So we should always make sure that each row should be uniquely identifiable. That is, there should be a primary key which should exist in a table so that there is a unique identification key in our table. Now let's see about each and every set of rule, and let's see that if in a given table, if it's not in first normal form, how we can make the given table in first normal form. So the first rule was atomicity. It says that each column should contain only indivisible atomic values, meaning each attribute should hold only a single value. There shouldn't be any attribute which should be holding multiple values. So here we can see that there is a table in which we are having columns as ID, person name and order, and here we can say that ID is having single values, person name is also having single values, but when we see the order column, we can say that there are multiple values which is present in the order column for a given person. So we can say that order is a multi-valued attribute because order is having multiple values. So we can say that this particular table is not in first normal form since it is having a multi-valued attribute. Now let's see that how we can achieve atomicity, or how we can make sure that our table is in first normal form. So there are three ways in which we can make a table in first normal form. So the first approach is, what we can do is, if there is a multi-valued attribute, we can repeat the other attributes twice or thrice depending on the values which is present in the multi-valued attribute, so that attribute can hold only single value. So here what we can do is, we can repeat the values in the ID and person name column twice, since we can see that there are two values for order for some of the entries. So we can repeat it twice to store single value of the multi-valued attribute order. So what we will do here is, we will write down all the columns or all the attributes which is present in our table, and then we will see that which is the multi-valued attribute. We will leave that particular attribute, and apart from that attribute, all the attributes which are present, we will repeat according to the values which is present in our multi-valued attribute. So here you can see that for Raj there are two orders, so we will repeat one Raj twice so that we can have single value for this particular order column. So first we will write one Raj, and then we will write the first order, that is muffin, and then we will write one Raj, and then the second order, that is sugar. Same we will do for Riti, but since Riti is only having a single order, so we will write Riti only for once, 2 Riti muffin, and then Rahul is also having two orders, so we will write 3 Rahul sugar and 3 Rahul egg. So now here we can see that this particular column order, which was earlier holding multiple values, is now only holding single values. So we can say that the multi-valued attribute is eliminated and there are only single values which is present in this table. So we can say that this particular table is in first normal form. Now what would be the primary key in this particular table? So here you can see that for a given ID, the person name is getting repeated twice. For one there is Raj, again for one there is Raj. So we can't say ID and person name would be a primary key. Let's see that if ID and order can be a primary key or not. So here you can see that there is ID 1 and then the order is muffin. Here there is ID 1 and then the order name is sugar. So here we can see that there is no repetition. So we can say that ID and order combinedly act as a primary key for this particular table. Now let's see the second approach. So in the second approach, what we can do is, we can make new columns for each multi-value which is present. So consider here the order is having at max 2 values. So what we can do is, we can make different columns. First we can make it as order 1 and second we can make it as order 2, so that it can store all the values which is present in order. So we will make the table as ID, person name, then we will make the column as order 1 and then second column as order 2. So we will just fill the data. So for one Raj there is one time muffin and the order 2 is sugar. So we will fill one Raj muffin sugar. Then coming to Riti, so for Riti there is only one order. So in order 1 we will fill muffin. But since there is no order 2 or there are no 2 orders, we will be filling value as null. Null basically means empty. Now coming to the third, for Rahul there are also 2 orders. So for the first order we will be entering sugar and for the second order we will be entering egg. In this approach, if you see, according to the values which is present in the order, we are making new columns. But consider that if there are 9 orders which are present, would you be making 9 order column, order 1, order 2 till order 9? That is not a feasible case, because for each and every order you need to fill null as a value for Riti. There could be more person in this particular table who are having only one order. So for them also you need to fill null. So this is not an approach which is always suggested, but since you can see that this particular table there is no multi-valued attribute, so we can say that it has converted the table into first normal form, but this is not a suggested approach. Now coming to the primary key of this particular table, so we can see that ID is something which is unique for each and every order, each and every person. So the ID would be acting as a primary key here. Now coming to the final approach. In final approach, what we will do is we will divide the table into two tables. First is the student table and second is the order table. So we'll see that order is the multi-valued attribute. So what we will do is we will divide the table into two tables. First table would be having ID and person name. Second table would be having order, but we need to maintain that this particular order belongs to which particular person or which particular ID. So we will be breaking it into ID as well as order. So there would be two tables. First is having ID and person name, second is having ID and order. So we will break the table based on the multi-valued attribute. Now here you can see that there is ID and person name, and ID is unique for each person and ID can uniquely identify each person. So we can say that ID is acting as a primary key here. And here you can see that there is a relationship which is established between two tables, because this particular table tells me that corresponding particular ID is having which order, and here it tells us that what is the name of a person corresponding to their ID. So we can say that there is a relationship which is established, and this ID is taking reference from this particular ID which is present here. So we can say that this is a foreign key as it is taking reference from the base table. So we have divided the table into two tables, base table and the referencing table. In the base table, there is a primary key which is acting as a foreign key in the referencing table. Now here you can say that order is now having only single values. It is having all the IDs which is corresponding to the given order, and this particular table has now been converted into the first normal form. So this was the last approach which we can follow, and this is kind of a best approach which we can follow because we oftenly divide the table and we can say that the data redundancy is also less. Yes, I do agree that in this particular ID column we can see some of the duplicate entries, but in this particular table we are not seeing any duplicacy, and in this particular table ID and order both are acting as a primary key. So ID and order both can together help me identify unique values, and here ID can help me identify unique values. So there is some level of duplicacy because normalization doesn't guarantee to remove the entire duplicacy, but the duplicacy is reduced in comparison to this case. Now before starting with second normal form, let's just re-revise about first normal form. So according to first normal form, in a given table, there shouldn't be any multi-valued attribute. So basically there shouldn't be any column which can hold multiple values. The values should always be atomic. That is, there should be always a single value. There shouldn't be multi-valued attribute present in a given table. Now coming to the second normal form. So a relation is in second normal form if it satisfies the following conditions. So the first condition it should always be in first normal form, and the second condition is it should not have any partial dependency, which means no non-prime attribute is dependent on any part of candidate key. Now candidate key is basically a unique identifier which helps us to uniquely identify records in a table. What is non-prime attribute? So we learnt about prime attributes and non-prime attribute. So consider that in a given table there are three attributes A, B and C, and AB is our candidate key. So the attributes which are a part of candidate key lies in the prime attribute, and the attributes which are not a part of candidate key lies in the non-prime attribute. So according to this, there shouldn't be any non-prime attribute that is dependent on any part of a candidate key. Now here we learnt about this term partial dependency. So let's understand what partial dependency exactly is. So what is partial dependency and when a partial dependency is there in a table? So a partial dependency is there in a table when the LHS is a proper subset of candidate key and RHS is a non-prime attribute. So whenever you are given any question, you are provided with all the attributes which are present in the table, then you are provided with the functional dependencies, like this particular attribute is determining this attribute or B is determining C. So these kind of functional dependencies are present in our table. Now according to partial dependency definition, we have to see if LHS is a proper subset of candidate key and RHS is a non-prime attribute. If these exist, then we can say that our table is not in second normal form because there is a partial dependency. So as the term suggests partial dependency, you can understand it in this way that a particular non-prime attribute is partially dependent on candidate key because it says a proper subset. So if a proper subset of AB is to be considered, so it will be A and B. It won't include AB in the set because that is a subset, not a proper set. So whenever we talk about proper subset, it will only contain A and B and not AB. So whenever there is a partial dependency, a part of candidate key is determining a non-prime attribute. So since a part of candidate key is determining, we can say that there is a partial dependency because a part is determining there is a dependency and there is a non-prime attribute which is getting partially determined. So we'll see about partial dependency in the next set of slides, but right now you can conclude that if a given table is not in first normal form, also if there is some partial dependency, we can say that the given table is not in second normal form. So what is a non-prime attribute? As I told, that non-prime attribute is an attribute that is not part of a candidate key. Now here you can see that there is a table. In this particular table, we have customer ID, we have order ID, and we have order name. So we have order ID, and according to the order ID, we have the order name. And here we have the customer ID of a customer who has placed this particular order. Now coming to this particular table, we have a candidate key as customer ID and order ID combination. So prime attribute would be the one which is a part of candidate key, that is customer ID and order ID. And since now order name is left, so order name will come in non-prime attribute because it is not a part of candidate key. So in this relation, you can see that order name is somehow dependent on order ID for its value. So if order ID is 1, the order name is muffin. If order ID is 2, the order name is sugar. So order name is somehow dependent only on the order ID. It's not dependent on the customer ID, because if I know the customer ID, I can't say the order name before even knowing the order ID. So because of that, the order name is having a dependency on order ID. But here we told that customer ID and order ID both are acting as a candidate key. And here a part of candidate key is determining a non-prime attribute. So we can say that there is a partial dependency. So according to order ID, we provide the order name, and order name is determined only by order ID. And here customer ID, order ID together are acting as a candidate key, but here only part of candidate key is determining the non-prime attribute. So we can say that there is a partial dependency. This particular table is not in second normal form. So how can we make the table in second normal form, or how can we normalize the table? So as I told, that normalization is basically breaking of tables into two or more subtables, or you can say decomposition of table into two or more subtables, so that the duplicacy or data redundancy is reduced. Also the data is consistent. So what we will do is we will divide this particular table into two tables. So now the question which would be coming to your mind is how we will even divide this table. What all attributes should be there in the first table, in the second table, or if there are three tables, how to divide this particular table. So what you can do is, firstly let's consider this table. So let's name the table as A, here the table is B, and here the table is C. Now in A, the candidate key is customer ID plus order ID, and we have order name which is kind of dependent on order ID. So if we know the order ID, we can get the order name. So what we will do is, we can see that order ID is something which is common between the non-prime attribute and the candidate key. So we will break the table on the basis of order ID, and we will try to have order ID in the next table as well, because in this way we won't lose the track of which particular customer has ordered which particular order. So we will divide the table into two or more subtables, and here the table is divided into B and C, and here the table is having customer ID and order ID, and here the table is having order ID and order name. So corresponding to the order ID, we have the order name, and here the customer ID has the order ID corresponding to which we can get the order name from the second table. Now here, can you see that in this particular table, we have the candidate key, that is customer ID plus order ID. But coming to this particular table, what should be the candidate key here? So here you can see that order ID is also getting repeated, order name is also getting repeated. So can we say that order ID and order name combined would be a candidate key? Yes, we can say that. So we will have order ID as well as order name combinedly as a candidate key. So now you can see that when the table is divided into 2 or more subtables, we have seen that now order name is directly dependent on order ID. There is no other candidate key which is present. And this is also a prime attribute. This is not a non-prime attribute because right now this is also a part of candidate key. So we can say that now there is no non-prime attribute which is getting determined by a part of candidate key. So in this way we can normalize the table. Now coming here, you can see that order ID is present here and in this table as well, in table B and in table C. Now here you can see that there is a relationship which is established. So here the customer tells that this particular order ID I have ordered, give me the order name. So you can see that there is a relationship between two tables which is being established, and it is established on the basis of order ID. So this particular order ID is taking reference from this table, that is B table. So we can say that order ID here is acting as a foreign key which is helping me to establish the relationship between these two tables. So let's solve a practice question in which we will be provided with some attributes, we will be provided with some functional dependency, and we have to say that if the given table is in second normal form or not. So let's see. So consider that there is a relation R which is having A, B, C, D as attributes. The functional dependencies which are provided are AB determines C, AB determines D, and B determines C. Now in this relation, find if this is in second normal form or not. So let's see what we will do. So the very first step is we will identify the candidate key in this given relation. So how to find the candidate key we have already discussed in one of our videos. So you can go ahead and watch it and then come to this video. So for candidate key, what we will do is firstly we will list down all the attributes which is present in our table. Secondly, what we will do is we will check for all the dependents if the determinants are present here. If it's present, then we will discard the dependents. So here the dependent is C. C is already present. So AB is the determinant. So we can discard C. Now it's ABD. Now coming to the next functional dependency, D is present here, and since AB is already present here, we can discard D. So now coming to the next functional dependency, here C is the dependent and B is the determinant. But since dependent is not present, we can't discard B. So at the last, we are left with AB. So what we will do is we will take the closure of AB and we will see that if it's determining all the attributes which is present in our table. So A can determine itself. B can determine itself from the property of reflexivity. B can also determine C, so we can write C. AB can also determine D, so we can write D. So AB can determine all the attributes which is present in our table. So we can say that AB is a candidate key and we can add it in the prime attributes. Now in the next step, there could be more candidate key. So for that, what we will do is, we will see that if AB is lying in any of the RHS, because if AB is someone's dependent and there is a determinant which can determine AB, we can replace AB with that, or ideally A or B with that. So let's see if A, B or AB is present in the RHS. So here it is C, here it is D, here it is C. So there is no A, B or AB present in the RHS, so we can say that there will be only one candidate key for this particular table, and that is AB. Now here we have found out that AB is the candidate key here. The step 2, we will check for the partial dependency to tell that if this given table is in second normal form or not. So for that, there should be 2 rules which should be followed. So first is LHS should be a proper subset of candidate key, and here we have found out that AB is the candidate key. So if we take the proper subset, we get A and B. So we have to check that if LHS is a proper subset of candidate key in a given functional dependency, and if RHS is a non-prime attribute. So since AB is a candidate key, we can say that AB lies in the prime attribute, and the rest attribute which is not a part of candidate key, we can say it lies in the non-prime attribute, that is CD. If these two exist, we can say that there is a partial dependency and table is not in second normal form. But if none of the dependency is having any partial dependency, we can say the table is in second normal form. So these were the functional dependency which were provided to us. This is the candidate key, that is AB. So the prime attributes are AB, the non-prime attributes are CD. So let's check for the first functional dependency. So we have to first check if LHS is a proper subset of candidate key or not. So AB is a candidate key, but there is no proper subset. Proper subset of AB is A and B, but it is combinedly present. So since there is no proper subset and since there is an AND condition, so we won't check for the second condition. AB is not a proper subset, it is a subset of AB. So we can say that this particular functional dependency doesn't have any partial dependency. Now coming to the second functional dependency. So again you can see that there is AB present. So there is not a proper subset of AB which is present, subset of AB is present. So we can also say that this particular dependency is also not having any partial dependency. So coming to the third functional dependency, that is B determines C. So here in the LHS you can say that B is a subset of AB, or you can say that B is a subset of candidate key. And according to these rules, if LHS is a subset of candidate key, we need to check for the second rule, and if second rule also applies, there is a partial dependency. So we'll check for RHS, and RHS is C, which is a non-prime attribute. And here according to this rule, RHS is a non-prime attribute and LHS is a proper subset of candidate key, then there is a partial dependency. So we can say that this particular dependency have some partial dependency, because of which this particular table is not in second normal form. So from this we can conclude that this particular table is not in second normal form, and also we have analyzed the dependency and we saw that one of the dependency was having some partial dependency. So that is why the table is not in second normal form. Now according to the first normal form, there shouldn't be any multi-valued attribute, or there shouldn't be any attribute which has multiple values. According to second normal form, there shouldn't be any partial dependency which should exist in a table. Now let's see what third normal form says. So according to third normal form, it should be in second normal form, like the table should be in second normal form. Second is, it shouldn't have any transitive dependency, which means that no non-prime attribute should be transitively dependent on a candidate key. So what is this transitive dependency? So transitive dependency occurs when non-prime attribute is dependent on another non-prime attribute. So whenever there is a non-prime to non-prime dependency, we can say that there is a transitive dependency. Let's understand transitive dependency in more depth. So consider that I have been given a project. Now for that particular project, I need some details, I need some books. So I'll go to a library A. Now that particular library borrows book from library B. So somehow you can say that for my project X, I want some books from library A, but library A is somehow borrowing some books from library B. So library A is dependent on B for the books, and I am dependent on library A for the books. So you can see that there is some transitive dependency which I am having with library B, because if the books are not present in library B, it will not reach to library A, and if it doesn't reaches to library A, I won't be getting that books. So this is called a transitive dependency, when I'm not directly dependent on something but indirectly dependent on something. So in this way we can say a partial dependency or a transitive dependency occurs in a table, and whenever there is a transitive dependency in a table, we can say that that particular table is not in third normal form. Now, there are two ways in which we can determine if a given functional dependency is following the third normal form or not. So if there is a transitive dependency, there would be a non-prime to non-prime dependency. Also, if we want to check that if there is no transitive dependency, so we can check for these two rules. That is, if X is determining Y is a functional dependency, then either X should be a super key or candidate key, or Y should be a prime attribute that is a part of candidate key. So if any one of these holds true, we can say that this functional dependency doesn't have any transitive dependency. So if there is no transitive dependency, X will always be a part of super key or candidate key, and Y will always be a prime attribute, because consider that here X is determining Y, and consider that Y is determining some Z, and since Y is a prime attribute and using the rule of transitivity, we can say that X will determine Z. So X is determining Z using a prime attribute. There shouldn't be any case where Y is a non-prime attribute, and using that non-prime attribute X is getting determined by Z. So this determining factor should always be a prime attribute, or we can say for the rule of transitivity to exist, the dependent should always be a prime attribute, and since X is determining Y, X should always be a part of candidate key or a super key. I know this might sound confusing, but now you can remember it in this way, that there shouldn't be any transitive dependency in the given table or in the given functional dependency, and how we can identify that there shouldn't be any non-prime to non-prime dependency, that if X determines Y is there as a functional dependency, X and Y both shouldn't be non-prime attributes. Either X should be a candidate key or super key, or Y should always be a prime attribute. So let's understand from an example. Consider that there is a relation ABCD with functional dependency AB determines C and C determines D. Find if it is in third normal form or not. So we need to check that if there is any transitive dependency. And for the transitive dependency check, we need to know that for this particular table, what are the non-prime attributes. So finding the non-prime attributes is very easy when we know the candidate, because all the attributes which are not part of candidate key lies in the non-prime attribute. So let's find the candidate key for this given table. So firstly what we'll do is we will note down all the attributes which is present in our table. Then we will check that for a given dependent, if its determinant is present and dependent is present or not. If its determinant is present, we can discard the dependent. So here we can see that C is the dependent and AB is the determinant. C is already present here, and if we have AB, it can always determine C. So we can discard C from here. So for the next functional dependency, we can see that D is present, D is the dependent and C is its determinant. So if the dependent is present, we can discard the determinant. But since C is not present here, we can't discard anything. But if you see closely to this functional dependency, it says that AB determines C and C determines D. So can we say that AB will determine D using the rule of transitivity? So we can say that if AB is present, it can already determine D. So if AB is present, it can already determine D. So we can discard this as well. So now we are left with AB. Now we need to take the closure of AB to see if it determines all the attribute which is present in our table. So A can determine itself, B can determine itself, AB will determine C, and C will determine D. So we can say that AB is a candidate key. Now we need to see that if any of this A or B is present in the right hand side of any of the functional dependency. If it's present, we can replace and find out more candidate key. If it's not present, then we can say that this is the only candidate key. So let's see. So in the right hand side of the first functional dependency, it's C. In the right hand side, it's D. So we can say that there won't be any more candidate key. So AB is a candidate key here. So we can say that AB is a candidate key here. Now in the next step, we need to check for the transitive dependency. If there is any transitive dependency, we can say that the given table is not in third normal form. If there are none of the transitive dependency, we can say that the given table is in third normal form only if the table is in second and the first normal form. So always keep this thing in mind that for a table to be in third normal form, it should always be in second normal form. If it's not in second normal form, we can't even say that the table is in third normal form. So from here we have find out that AB is the candidate key. Let's find the prime and the non-prime attribute. So prime attributes are the one which are the part of candidate key, that is AB, and non-prime are the one which are not a part of candidate key, that is CD. So in this particular table, we have found out the candidate key, we have found out the prime attribute, and we have found out the non-prime attribute. Now let's see that if there is any non-prime to non-prime dependency existing in the table or not. So there are two functional dependency. For the first functional dependency, AB determines C. So is AB a non-prime attribute? No, neither of A nor of B are a non-prime attribute. And is C a non-prime attribute? Yes, C is a non-prime attribute, but since AB is not a non-prime attribute, we can say that there is no transitive dependency as AB is a candidate key or a super key. Now coming to the next functional dependency, C determines D. Now here C is a part of non-prime attribute. So the first condition is agreeing that there shouldn't be any non-prime attribute in LHS. Now coming to RHS, D is also a part of non-prime attribute. So RHS is also having a non-prime attribute. So there is a non-prime attribute which is determining a non-prime attribute. So we can say a transitive dependency is existing because C is not a super key or candidate key, or D is a prime attribute and a non-prime to non-prime dependency is existing where a non-prime attribute is determining a non-prime attribute. See, prime attribute can determine a non-prime attribute, non-prime attribute can determine a prime attribute can also determine a prime attribute, but there shouldn't be any dependency where a non-prime attribute is determining a non-prime attribute. So till now we have discussed on this non-prime to non-prime dependency, but do you even wonder that why this particular dependency, if exists in a table, we say that table is not in third normal form. So consider an example that there is a table. Now in this particular table, we oftenly find the primary key or the candidate key because that act as a unique identifier. So consider that there are three columns A, B and C. So here A is acting as a key, either you can say primary key or candidate key. Now why do we even need key in a table? So basically key help us to uniquely identify records in a table. If I know the value of A, I can tell the value of B and C. But consider that there is a case where I know the value of B. Would I be able to tell the value of C or A? Consider that here the value of B is 1 and 1 and here the value of C is 4 and 5. So if I tell you that the value of B is 1, tell me the value of C. So if you look here, for 1 it is also having the value as 4, for 1 it is also having the value as 5. So would the value of B help me to find the value of C? No, it would not help me, right? So for that purpose only we have a key. We can say candidate key, super key, primary key in a given table so that we can uniquely identify our records. If I know the value of A, I can tell the value of B and C for that particular value of A. So for that particular purpose, we have a candidate key, and when there is no candidate key or no prime attribute or super key which is determining something, we can say that we won't be able to determine anything because now the dependent values can be different. So for the dependent values to remain same, we need to have a candidate key or super key as a determinant because it will help me to identify the values. So that is why there shouldn't be any non-prime to non-prime dependency, because there should always be a determinant which should be a candidate key which can help me to find the value of dependent. So the very first question which would be coming to your mind is, why do we even need to learn about Boyce Codes normal form if we have already learnt about third normal form? And you are saying that this is a refinement to the third normal form. So what was the issue in third normal form? So if you remember, according to third normal form, if there is a dependency X determines Y, X should either be a super key or a candidate key, or Y can be a prime attribute. So because of this OR, we were encountering some anomalies and some data redundancy. Let me explain you why. So consider there is a relation R which is having attributes as A, B, X and Y. In this particular relation R, B and Y are prime attributes and X is a candidate key. So consider there are two functional dependency, X determines Y, A determines B. So in this, since X is a candidate key, we can say that it follows the third normal form rule. So this particular functional dependency is in third normal form. Now coming to this dependency, here A is neither a candidate key or super key, but here B is a prime attribute. So because of this, we can say that this particular functional dependency also follows the third normal form rule. But here A wasn't a candidate key or super key, because of which there was some data redundancy or duplicacy which was there, and it was causing some certain anomalies to be present in our table. Now because of that, the Boyce Codes normal form was introduced so that we can add some refinement to the third normal form. Now according to Boyce Codes normal form or BCNF, a relation should be in third normal form. Second, for a given functional dependency X determines Y, X should always be a candidate key or super key and should only determine non-prime attributes. So according to the Boyce Codes normal form, it says that there shouldn't be any OR condition. X or the determinant should always be a candidate key or super key so that there is no data redundancy or the data redundancy is reduced. So let's understand from an example. Consider that there is a relation R which is having attributes as A, B, C and D, and there are some functional dependencies which are provided. So find if this particular relation is in BCNF or not. So what we will do is, first we will identify the candidate key. So let me just write down all the attributes which is present in our table, and then we will see if the dependent is present here or not, and if its determinant is also present here or not. If it's present, then we can discard the dependent. So C is the dependent and its determinant is AB. So since C is present, AB can determine C, so we can discard C. Now ABD is present. Now coming to this functional dependency, D is the dependent and AB is the determinant. D is also present and AB is also present. So we can discard the dependent, and now AB is present. Now there are no functional dependencies, so what we will do is we will take a closure of AB. So it will give me A, B, C and D. And there is no proper subset of AB which will give me all the attributes. So I can say that AB is a candidate key. So AB is the candidate key here. Now as part of second step, we have to check for the candidate key or super key in LHS. So these are the functional dependencies. So coming to the first functional dependency, since AB is the candidate key and AB determines C, we can say that LHS AB is a candidate key, so it follows the Boyce Codes normal form. Now coming to the second functional dependency, that is AB determines C, since again AB is a candidate key, so this also follows the BCNF rule. So we can say that this particular relation is in BCNF. Let's just re-revise some older concepts and then we will switch to the decomposition. So consider there is a relation R. Now this particular relation R has some rows, has some columns and has some data present in it. Consider that there is a data redundancy, or you can say data duplicacy, which is present in this particular table or this particular relation. So what we will do is we will normalize the relation. So what we do in normalization is we break or decompose the given relation into two or more sub-relation so that the data redundancy or data duplicacy is decreased. So we have broken it into R1 and R2. Now this particular decomposition can be of two types. First is a lossy decomposition and second one is a lossless decomposition, which we will be knowing in this particular video. So in normalization, we generally break or decompose the table into two or more subtables. Now consider if there is a relation R, lossy decomposition occurs when a relation R is decomposed or broken into two or more relation, but the data is lost. So basically in this kind of decomposition, the data is lost and the original relation R can't be reconstructed by joining these decomposed relation. So if there is a relation R which is broken or decomposed into R1 and R2, and consider that if I want to find some data which is present in R1 as well as R2, I perform a join operation between them, and after performing the join operation I get R3. So according to the definition of lossy decomposition, R3 would never be equal to R, which was our base table. So some data is lost and some data may be repeated as well. So the data which is present in R3 is not equal to the data which is present in R. Basically data is not preserved. So there are two rules for decomposition to be lossy. The first rule is some data from the original relation R is lost after decomposition. So R3 is not equal to R. Second is join of the decomposed relation R1, R2 till Rn, if there are n number of relation, is not equal to the original relation R. So after getting decomposed and performing the join operation, the resulting relation is not equal to the base relation, or you can say the relation R, which was the original table. So let's understand lossy decomposition from an example. So consider that there is a relation R which is having attributes as A, B and C. So this is the relation R which is having attributes A, B and C. So what we will do in step 1 is we will decompose the relation based on any attribute. So we can choose any attribute and we can decompose the table based on that attribute. Consider that we are choosing B. So we'll decompose the table into AB and BC. So for now, let's use B as the common attribute. Decomposed relations are R1, R2. R1 is having A and B and R2 is having B and C, and the value remains the same. So A is 1 and 4, A is 1 and 4, B is 2 and 2, C is 3 and 6. So all the values remain the same. It's just that we have broken the table vertically from B, and B is the common attribute which is in the relation 1 as well as in the relation 2. Now step 2 is let's perform a natural join between R1 and R2. So what is this natural join? Join is basically a cross product plus some condition. So whenever we perform a cross product and then we provide some condition and on basis of that we filter the data, we perform join. Now coming to the natural join. So what happens in natural join is we do the cross product, and then the condition in natural join is that the attribute which is present in relation 1 should be equal to the attribute which is present in relation 2. So on basis of this, we will filter out the data. So let's perform a natural join between R1 and R2. So what we will do is first we will do a cross product. So for the cross product, the first row of R1 will be cross product with both the rows of R2. Then the second row of R1 will be cross product with both the rows of R2. And then we will filter the data based on the condition. So what we will do is first we will note down the values of R1, that is 1 and 2. Now 1 and 2 will be cross product with 2 and 3 of R2. And then 1 and 2 will again be cross product with 2 and 6. Now coming to 4 and 2. So 4 and 2 will be cross product with 2 and 3. And again 4 and 2 will be cross product with 2 and 6. Now what we will do is we will follow the condition that the common attribute should be equal. So R1 of B should be equal to R2 of B. So this is AB and this is BC. So let's see if R1 of B is equal to R2 of B. Yes. So this will be in our final result. Coming to this, R1 of B is equal to R2 of B. Yes. So this will also be in our final result. Coming to third, R1 of B is equal to R2 of B. Yes, so it will be also displayed in final result. Coming to the last one, R1 of B is equal to R2 of B. Yes, so this will also be displayed in the final result. So the final relation we will get after the join is 1, 2, 3, 1, 2, 6, 4, 2, 3 and 4, 2, 6. Now this was our original relation which has 1, 2, 3, 4, 5, 6. And this is the relation after we perform the natural join. So here you can see 1, 2, 3. which is present here as well. But coming to 4, 5, 6, it is not present here. So we can see that data is lost, and we can also see some additional fields which is present here. So we can clearly say that R3 is not equal to R because some data is also lost and some extra data is present. So this is a lossy decomposition. So we saw in the lossy decomposition that our data was also lost and there was some extra set of data which was also present. But now we have to make sure that even if the decomposition happens, the data is not lost. So that is a lossless decomposition. So whenever we see a lossless decomposition, it basically means whenever the decomposition happens and if there is a join operation which is performed between both of these relations or the decomposed relation, we don't lose the data. The data is preserved. So let's see that how we can ensure that the decomposition is a lossless decomposition. So the first pointer is divide or decompose the table on the basis of candidate key or super key present in the relation so that there is no duplicacy. So as we can also see that in the lossy decomposition there was some duplicacy, there was some extra data which was present. So we have to make sure the attribute on basis of which we are dividing the table should either be a candidate key or should be a super key, so that this unique identifier will help me to eliminate the duplicate data. Now coming to the second pointer, for a decomposition to be lossless, first is R1 union R2 should be equal to R. So whenever we do a union between the decomposed table, it should always result into the original table. Now the second one is R1 intersection R2 should be equal to the common attribute. So consider if our relation is broken down into R1 and R2, and R1 is having AB as the attribute and R2 is having BC as the attribute. So whenever we do an intersection between them, it should result into the common attribute which is present between this relation. So R1 intersection R2 should result into the common attribute. Third pointer is to ensure that a decomposition is lossless, a common approach is to use the dependency preservation property. Now we will learn about this dependency preservation property in next set of videos, but for now you can keep these two pointers in mind so that a decomposition is not lossy, it's lossless. Now coming to the lossless decomposition. So consider that there is a relation R. So in lossless decomposition, it ensures that when a relation R is decomposed or breaked into two or more relations, no data is lost. That is, the original relation R can be again reconstructed by joining these decomposed relations. So if there is a relation R which is decomposed into R1 and R2, and whenever we perform a natural join or a join between them, if we get R3, so the data which is present in R is equal to the data which is present in R3. So the data is preserved and we get the original table after performing the join operation. So there are two rules for a decomposition to be lossless. First one is all data in the original relation R should be preserved after decomposition, and second is join of the decomposed relations is equal to the original relation. So let's understand from an example for the lossless decomposition. So consider there is a relation R having attributes as A, B and C, and the candidate key here is given as A. So what we will do in the lossless decomposition is we will divide the table on the basis of the candidate key, and that would be a common attribute. So let's decompose the relation based on the candidate key or super key of given relation. So the decomposed relation would be R1 which will be having A and B, and R2 which would be having A and C. Since A is the super key or candidate key, so this would be a common attribute. Now these are the relations R1 and R2. So let's perform a natural join between them. Now whenever we perform a natural join between two relations, what we do is we do the cross product among two relations and then we perform a condition between them, that is the common attribute in R1 should be equal to the common attribute in R2. So first we'll do the cross product. So first this row will be multiplied with all these rows. So 1, 2 is multiplied with 1, 3. Then again 1, 2 is multiplied with 4 and 6. Now coming to the second row. So 4 and 5 will be cross product with 1 and 3. And then again 4 and 5 will be cross product with 4 and 6. Now let's check for this condition where R1 of A should be equal to R2 of A. So this is R1 of A and this is R2 of A. So R1 of A is equal to R2 of A. Yes. So 1, 2, 1, 3 will be in the final result. R1 of A is equal to R2 of A. No. So this should be discarded from the final result. R1 of A is equal to R2 of A. No. So this should also be discarded from the final result. R1 of A is equal to R2 of A. Yes. This should be present in the final result. So if you see the original relation, it has 1, 2, 3, 4, 5, 6, and if you see the relation after natural join, it also has 1, 2 and 3, and 4, 5 and 6. So the relation which we get after performing a natural join on the table is same as the original relation. So in step 2, let's perform a natural join between R1 and R2, and whenever we do R1 natural join R2, we get the original relation back. So consider this is a relation R3. So R3 is equal to R, because all the data which is present in R is present in R3. So that is why this is a lossless decomposition. As the word suggests, dependency preserving decomposition. So whenever we are having decomposition, or whenever we are in a process of having decomposition, if the functional dependency before the decomposition and after the decomposition are preserved or maintained, we call it as dependency preserving decomposition. So dependency preserving decomposition ensures that the functional dependencies are preserved or maintained after decomposing a relation into two or more smaller relations. So it makes sure that the functional dependencies are preserved before the decomposition as well as after the decomposition. Now here consider an example. So consider a relation R which is having attributes as A, B and C with functional dependencies as A determine B and B determine C. Find its dependency preserving when it's divided into relation R1 which is having A and B and relation R2 which is having B and C as the attribute. So here we have a relation ABC which is now divided into two relation R1 and R2, where R1 is having AB as the attributes and R2 is having BC as the attribute. Now we have to see the functional dependency which was there before the division or before the decomposition is preserved or maintained or not. Now coming to the first relation, that is R1. So it is having attributes as A and B. Now if we want to form a functional dependency using these attributes, what can we form is A can determine itself, B can also determine itself. These are trivial dependency, or we can say the property of reflexivity. Now A can also determine B. These functional dependency we have derived. Now coming to the trivial dependency, we generally don't care about trivial dependency because it always holds true. So for this we don't need to look at. Now coming to these, is there any functional dependency which is present here which is also here? So we can see that A determines B is there before the decomposition and A determine B is also there after the decomposition. So we can say that this particular functional dependency is preserved using this particular decomposition table. Now coming to the second table, that is R2 which is having attributes as B and C. So the trivial dependencies could be B determine B, C determine C, but we don't need to take care of trivial dependency. So coming to the non-trivial one, so it could be B determine C. So among these functional dependency, let's see if there is any dependency which is preserved even after decomposition. So you can see B determine C is here as well and here as well. So before and after the decomposition, B determines C is preserved. So in this particular table, BC, B determines C is preserved. So both of the functional dependencies is preserved. So we can say that the decomposition is dependency preserving because the functional dependency A determine B and B determine C are preserved in relations R1 and R2. Now let's see one more example so that the concept is clear. So consider there is a relation R which is having attributes as A, B, C, D and the functional dependencies are A determine B, A determine C, C determine D. Find if it's dependency preserving when divided into R1 ABC and R2 CD. Coming to the first relation, that is R1 which is having attributes as A, B and C. So since this R1 is having attributes as A, B and C, there could be some functional dependencies which would be present. So first what we will do is we'll take the closure of A. So if we take the closure of A, it will give me A, B, C and D, all the attributes. Coming to the closure of B, it will only give me B. Coming to the closure of C, it will give me C and D. So from here we can say that A can determine A can determine B, A can determine C, A can determine D. So we can make the functional dependency as A determine B and A determine C. Now coming to B, B can only determine itself, so we will discard it. Coming to C, so C can determine itself and C can determine D, but there is no D present in this particular relation. So these two would be the functional dependencies which would be for this particular relation. And coming to the functional dependency which was present before, so we can say that A determine B is a functional dependency which is preserved here. Coming to A determine C is also a functional dependency which is preserved here. So we can say that for the first table A, B, C, A determine B and A determine C is preserved. Now coming to the second table, that is R2, which is having C and D. Now from C and D, C can determine C and C can determine D. So there would be only one functional dependency, C determine D. And now if we see to the functional dependency which was present before the decomposition, there is a C determine D, and after decomposition also C determine D is there. So C determine D is also preserved. So the decomposition is dependency preserving because the functional dependency A determine B and B determine C are preserved in R1 and R2. So if you want to find that if a given relation is having dependency preserving decomposition or not, what you can do is you can note down the relation and then you can find out the decomposed table of that particular relation. For the original relation, you can note down the functional dependency. For the decomposed relation, you can find out the functional dependency using the closure method, where you can find the closure of individual attributes, and when you have find the closure of individual attributes, you can know which all attributes that particular closure can define, and then you can derive some functional dependency based on that. Once you have derived the functional dependency, you need to check if the functional dependency which is derived after decomposition and if the one which was present before decomposition is preserved or not. In this way, you can find out if a given relation or if a given functional dependency is dependency preserving or not. Now, what is fourth normal form? So, a relation is said to be in fourth normal form if it satisfies the following condition. So, the first condition is it should be in BCNF, that is Boy's code normal form. Second is it shouldn't have any multi-valued dependency. Now, what is this multi-valued dependency? So, a multi-valued dependency, X determines Y, X determines Z, in a relation R, XYZ implies that for each value of X, there are a set of values of Y and set of values of Z that are independent of each other. So according to multi-valued dependency, if X is having a multi-valued dependency on Y, so for every value of X, there would be multiple values of Y. Or if X is having a multi-valued dependency on Z, so for every value of X, there would be multiple value of Z. So let's understand from an example. Consider that there is a relation student which is having student ID, student course and student phone number. Now one particular student can have multiple course, one particular student can also have multiple phone numbers. So let's see from this relation. So here you can see that the student ID is 1, but the course he has taken is maths and the phone number is 123. Again the student ID is 1, the course he has taken is science and the phone number is 123. Now again coming to the student ID is 1, the course he has taken is maths, but now the phone number is 345. So we can say for a student ID 1, the course is maths and science and the phone number is 123 and 345. So you can see for a given student ID, we are providing 4 entries. Now again coming to student 2, so student 2 has taken Hindi and English and the phone numbers are 678 and 910. So here you can see that there is so much of redundant data. So let's see that how we can decompose the table and get rid of this redundant data. So this was our base table or original table. Now it has been split into 2 tables. And the common attribute between them is student ID. So what we have done is we have split the table into student ID and course and then student ID and phone number. Now here you can see that student ID is only having 2 entries and the course is mentioned for that particular student ID. And now coming to the second table, it has happened in the same way that the student ID is now mentioned only 2 times and the phone number corresponding to the student ID is mentioned. So you can say that the data redundancy or data duplicacy is reduced here, and since we have decomposed the table, we have often normalized the table. So this now fifth normal form, or we can also call this project joint normal form, that is PJNF. So a relation is said to be in fifth normal form if it satisfies the following condition. First is it should be in fourth normal form. Second is the decomposition should be lossless. Now what is this lossless and lossy decomposition? So we have already learned about lossy and lossless decomposition in last set of videos. You can go ahead and have a look. But just to re-revise, let's have a look again. So consider that there is a relation. Now this particular relation have some redundant data. So according to normalization, we normalize or we decompose the table into 2 or more subtables so that the data redundancy is less. Now this particular decomposition of relation can be of 2 types, lossy and lossless. Now in lossy decomposition, we often lose the data or data is lost or data is not preserved, and in lossless decomposition, the data is preserved even after decomposition. So data is preserved. So consider that if we have divided the relation or decomposed the relation into R1 and R2, and if we are performing a join operation between R1 and R2, which is giving me R3, so according to lossless, R3 would be equal to the original relation, that is R. So all the data which is in R3 would be equal to the original relation. But in lossy decomposition, R3 wouldn't be equal to R, because in lossy decomposition, we often lost the data. So the decomposition should be lossless for a relation to be in fifth normal form. Now lossless decomposition, it ensures that when a relation R is decomposed or break into two or more relation, no data is lost, and the original relation R can be again reconstructed by joining this decomposed relation, that is R3 is equal to R for the lossless decomposition. Let's understand from an example. So consider that there is a relation R which is having attributes as A, B and C, and the candidate key is A. So often in lossless decomposition, we decompose the table on the basis of candidate key and make it as a common attribute between both the decomposed relations. So step 1 is, let's decompose the relation based on the candidate key or super key of the given relation. So decomposed relation are R1 AB and R2 AC. So this was our original relation which has A, B and C, and now it's decomposed to A, B and AC. Now whenever we perform a natural join between R1 and R2, so natural join is basically a cross product plus some condition. The condition is the common attribute in R1 should be equal to the common attribute in R2, on basis of which we have divided the table or we have decomposed the table. So after doing a natural join, we see that R3, or you can say R1 natural join R2 is same as the original relation. So all the data 1, 2, 3, 4, 5, 6 is preserved in this particular relation as well. So step 2, let's perform a natural join between R1 and R2. And whenever we do a R1 natural join R2, we get the original relation back, that is lossless. So we can say that this particular table or this particular relation is in fifth normal form because the decomposition is lossless, and it is also in fourth normal form. So how to find the highest normal form of a given relation? So the step 1 is, we have to identify the candidate key for the given relation using the functional dependencies which are present and the closure method. Now the step 2 is, we have to find the prime and non-prime attributes for the given relation. So prime are basically the ones which are part of candidate key, and non-prime are the ones which are not the part of candidate key. Now the step 3 is, we have to check for the normal forms one by one according to their rules. So all the normal forms have some specific rules. We have to see that if the functional dependency corresponds to the given rule or not. Now here you can see that there is a box which I have drawn. First is first normal form, second is 2NF, third is third normal form, and fourth one is BCNF. So it says that if a given relation is in BCNF, it is always in third normal form, second normal form, and first normal form. If a given relation is in third normal form, it will always be in second and first normal form. If a given relation is in second normal form, it will always be in first normal form. And if a given relation is in first normal form, then it's in first normal form. So if any relation is present, if we check if the given relation is in BCNF or Boy's code normal form, we can say that it is in third normal form, second normal form, and first normal form. If a given relation is in third normal form, we can say it is in second and first. If a given relation is in second normal form, we can say it is in first normal form. So this is the box, or this is the pattern which it follows. If a given relation is in BCNF, we can say that it follows all the three normal forms. So let's find out that how we can find the highest normal form for a given relation using this problem statement. Generally, we should start with BCNF, because if a given relation is in BCNF, we can say that it is in third normal form, it is in second normal form, and it is in first normal form. So if we start with BCNF, it would be very easy task. If we start with finding the first normal form, then we need to find the second, third and fourth as well. But if we start with BCNF, and if a given relation is in BCNF, we can say that it is in third, second as well as first. But here I'll be starting with finding the first normal form, second, third and BCNF, because I want to explain about each and every normal form. But whenever you get question, always start with BCNF so that you can find out that if a given relation is in BCNF or not. If it fails, then go for third normal form. If it also fails, then go for second, and if it also fails, then go for first. But it's better to start with the highest normal form. So let's start. So the first step is we have to find the candidate key for the given relation. So to find the candidate key, first we note down all the attributes which is present in our table. Then we iterate to the functional dependency and we check if the dependent and determinant is present. If both of dependent and determinant is present here, we can discard the dependent because it can eventually be determined. So BC is the dependent and A is the determinant. Both are present, so we can discard BC. So we are left with A. Now coming to this functional dependency, C is the dependent, B is the determinant, neither of them is present. Coming to this, B is the dependent, A is the determinant, A is present but B is not present, so we can ignore this. Now coming to this, AB is the determinant, C is the dependent, A is present but B and C are not present. Coming to this, A is the dependent and B is the determinant, A is present but B is not present. So A is a possible candidate key. So let me find the closure of A. So closure of A gives me A provides me A, then A gives me B, then A gives me C, and then okay. So A, B, C are all the attributes which are present in our table. So A closure gives me all the attributes which are present in our table. Now we have to see that if A lies in the right hand side of any of the functional dependency. So we can see that A lies here. So we have to take the closure of B as well, because it could also be a possible candidate key. So let me find the B closure. So B can determine itself, B can determine C, and B can also determine A. So B closure can also determine all the attributes, and proper subset of them are neither a super key or a candidate key. So we can say that A and B are candidate keys. So candidate key here are A and B. Now in the second step, we have to find the prime and non-prime attributes. Prime are the one which are the part of candidate key, so we'll mention AB here. Non-prime are the one which are not the part of candidate key, that is C. Now third is we have to check for the normal forms one by one according to their rule. Again, I am reiterating that we should always start checking from the BCNF, because that is the highest normal form, and if a given relation is in BCNF, it is in third, second and first normal form. So always check from the highest normal form. Here I am starting with the lowest normal form because I want to discuss on each and every normal forms and show you that how we can say that a given relation is in given normal form. So let's start with the first normal form. So a relation is in first normal form if it contains only atomic values, that is there shouldn't be any multi-valued attributes, like a attribute which is having multiple values, you can say phone number. So if an attribute is having multiple values, we say that this particular relation is not in first normal form. But here, since we are using a standard relational model, so we can say that it is already in first normal form. Now coming to the second normal form. So second normal form, a relation is in second normal form if it is in first normal form, that is already true, and every non-prime attribute is fully functional dependent on every candidate key of the relation. That is, there shouldn't be any partial dependency. And when partial dependency occurs, when LHS is a proper subset of candidate key and RHS is a non-prime attribute. So if this holds true, we can say that the given relation has partial dependency, so it's not in second normal form. So we have A and B as the candidate key. If we take the proper subset of A and B, that is 5, basically empty, because there is no proper subset of A and B. Now coming to the RHS is a non-prime attribute, so we know that C and D are the non-prime attributes. So let's check for each and every functional dependency. The very first one is A determines BC. Since A is a candidate key and not a part of candidate key, we can say there is no partial dependency, because if it fails here, we don't need to check for the second condition. Now coming to B determines C, B is also a candidate key, not a proper subset of candidate key, so no partial dependency. Coming to third, A is again a candidate key, so we don't need to check for the second condition. Coming to fourth, AB both are a candidate key, so no partial dependency, as AB is a combination of candidate key, it is acting as a super key. Now coming to B determine A, again B is a candidate key, it's not a proper subset of candidate key, so we can say there is no partial dependency. So we can say that the given relation is in second normal form. We didn't check for the second rule because the first rule was holding false for each and every functional dependency, and if there is a false and if we do AND with any of the false, it gives false. Now coming to the third normal form. So a relation is in third normal form if it is in second normal form and there is no transitive dependency which is existing. So we have to check that if there is a relation X determines Y, X is a super key or a candidate key, or Y is a prime attribute. If this is true, we can say that the given relation is in third normal form. So this particular rule basically says there shouldn't be any transitive dependency. So let's check for each and every functional dependency. So here A determines BC. A is a candidate key, so no transitive dependency. B determines C. B is a candidate key, no transitive dependency. A determines B. A is a candidate key, no transitive dependency. AB determines C. So A and B both are candidate keys, and when we put A and B together, that is a super key, because candidate key is a minimal super key. So A and B together acts as a super key and X is a super key, so there is no transitive dependency here, as AB is the combination of candidate keys, it's super key. Now coming to B determine A, B is again a candidate key, so there is no transitive dependency. So we can say that this particular relation is also in third normal form. Now coming to the fourth one, that is BCNF. So a relation is told to be in BCNF if it follows the third normal form, and for every functional dependency X determines Y, X is super key or you can say candidate key. So let's see for each and every functional dependency. So A determine BC, A is a candidate key, so it is in BCNF. B determines C, B is a candidate key. A determine B, A is a candidate key. AB is a super key, and B determines A, B is a candidate key. So we can say that the given relation is in BCNF as well. So the highest normal form for the given relation is BCNF. So we have already learned about normalization, types of normal forms and much more things. Now let's see that how we can normalize a table. So in normalization, we generally break or decompose the table into two or more subtables. Now how would that decomposition happen? How would we know that we have to decompose the table and how we should decompose the table? So let's see the steps to normalize a table. So the very first step is we have to write down all the attributes of the table, candidate key, prime and non-prime attributes, and start analyzing with the functional dependency. So in the question, we would be provided with a relation and their functional dependency. We have to find out the candidate key, prime, non-prime attributes, and we have to start analyzing the functional dependency. So the second step is for the table to be in first normal form, table should have atomic, that is indivisible or you can say single values, and have a primary key. For the table to be in second normal form, there shouldn't be any partial dependency. So when partial dependency occurs is when LHS is a proper subset of candidate key and RHS is a non-prime attribute. This should be false for the table to be in second normal form. Now coming to the fourth step, that is for the table to be in third normal form, there shouldn't be any transitive dependency. That is LHS must be a candidate key or RHS should be a prime attribute, that should be holding true. Now coming to the fifth step, for a table to be in BCNF, LHS must be a candidate key or super key. Now coming to the sixth step, if it fails at any of these steps like second, third, fourth and fifth, where we are finding about first, second, third and BCNF, then we have to decompose the table on a common attribute which is a candidate key so that the decomposition is lossless, that is data is not lost. So let's understand from a practice problem where we have provided a relation, we have been provided with a functional dependency, and we have to see that if the table is normalized or not. If the table is normalized, we will check for the higher normal forms. If it's not normalized, we will decompose it and then again check for the higher normal form. So we will check till BCNF that if the table is normalized or not. So the step one is we have to find the candidate key, prime attribute, non-prime attribute and start analyzing the functional dependency. So to find the candidate key, first we will note down all the attributes of the given relation. Then we will iterate with the function dependency and we will see if the dependent and determinant are present or not. If both of them are present, then we can discard the dependent because it can be determined. So the first functional dependency is A determine B. B is the dependent and A is the determinant. Both are present, so we can discard the dependent. So now we are left with ACD. Now coming to the next functional dependency, B determines C. So C is the dependent and B is the determinant, but B is not present here, so we have to leave this functional dependency. Now coming to where C determines D. So D is also present here and C is also present here, so we can discard D. Now we are left with AC. So from here you can see that A determines B and B determines C. So can we say that A will also determine C from the rule of transitivity? So we can see that A determines C and A and C both are present here, so we can discard the dependent, that is C. So we are left with A, and if we take the closure of A, it will give me A, it will give me B, B will give me C and C will give me D. So we can say that A is a candidate key. And now we have to see that if A is present at the right hand side of any of the functional attributes. No, it's not present. So we can say that A is the candidate key. So here candidate key is A, prime attribute are the one which are part of candidate key, so A is here, and non-prime are the one which are not a part of candidate key, so that is BCD. So in step 2, since we have found out the candidate key, prime and non-prime attribute, we have to check for the first normal form. So since we are assuming that our relation is in standard relational model, it is already in first normal form. So here we can see all the values are atomic only because it is a standard relational model. Now coming to the step 3, that is we have to find for the second normal form. So to check for the second normal form, we have to check that if there is any partial dependency present or not. If it's present, then it's not in second normal form. If it's not present, then we can say it's in second normal form. So coming to the first functional dependency, that is A determine B. A is already a candidate key and the proper subset of candidate key is pi. So we can say that there is no partial dependency as A is not a proper subset of candidate key and B is non-prime. So false and true gives us false. There is no partial dependency. Now coming to B determine C. So B is not a proper subset of candidate key. And coming to C, so C is also a non-prime attribute. So LHS must be a proper subset of candidate key and RHS should be a non-prime attribute. So this is true, but this is false. So false and true gives us false. So coming to the third functional dependency, C is not a proper subset of candidate key. So we can say LHS is not a proper subset of candidate key. D is non-prime attribute. So this is false and this is true. So false and true gives us false. So this one is also not having any partial dependency. So we can say that the given relation is in second normal form. Now let's check for the third normal form. So for third normal form, there shouldn't be any transitive dependency. That is, LHS must be a candidate key or RHS must be a prime attribute. This should be true. So let's check. So first is LHS. Is LHS a candidate key? Yes. So we can say there is no transitive dependency as LHS is a candidate key. And this is in OR, so this is true. So we don't need to check for this. Now coming to this functional dependency, is LHS a candidate key? No. So we have to check if RHS is a prime attribute. Is RHS a prime attribute? No. So we can say there is a transitive dependency as LHS is also not a candidate key and RHS is non-prime attribute. Now coming to this particular dependency, is LHS a candidate key? No. Is RHS a prime attribute? No. So we can say there is a transitive dependency here as well. Now we have found out that there are two transitive dependencies which are present in two functional dependency. So we have to decompose this table. So we have to decompose this table ABCD into three tables because here we can see that there are two functional dependency in which there is a transitive dependency. So one would be divided in such a way that there is BC and one would be divided in such a way that there is CD and the rest would be left here. So that is A determine B. So it will be divided into AB, BC and CD. So now the relation is divided into three, AB, BC, CD, where BC and CD were having some transitive dependency before decomposition and AB was not having any transitive dependency. Now the table is divided into three relations, that is R1, R2 and R3. Now again we have to check for the third normal form. So coming to this relation, this was already in third normal form, so we don't need to check because A determine me was not having any transitive dependency. So coming to this relation where we have BC, where B is determining C. So we can say that for this particular relation, B is acting as a candidate key as B is determining C. So now B is candidate key and according to third normal form, LHS must be a candidate key. So we can say that now there is no transitive dependency. Coming to this table, that is CD. Now in this particular table, C determines C is the functional dependency and now C is determining D. So we can say that C is acting as a candidate key. So we can say now candidate key is present in LHS, so there is no transitive dependency. So after decomposition, the transitive dependency is removed. Now we have to check for BCNF. But now since the table is decomposed into three tables, so we have to check for three of them individually. So let's check for the relation 1, that is AB. So A will determine B and A is the candidate key here. So since A is the candidate key or super key, so R1 is in BCNF. Now coming to the second relation, that is BC, where B is acting as a candidate key and the functional dependency is B determines C. So since B is a candidate key or super key, so R2 is in BCNF because according to BCNF, LHS must be a candidate key or super key. Now coming to third relation, CD, where C determines D is a functional dependency and C is acting as a candidate key. So we can say that this one is also in BCNF. So now all decomposed relations R1, R2, R3 are in BCNF. So in this way we normalize a relation or a table. We generally decompose the table or relation whenever we find out that it's not following a certain normal form. Now consider that if you are given two functional dependency set A, or you can say relation A is having some functional dependency, relation B is also having some functional dependency, and we have to check the functional dependency which is of relation A and relation B are equivalent or not, or have a equivalence relationship or not. So for that we use the concept of equivalence of functional dependency. So what is functional dependency? A functional dependency X determines Y, where X is the determinant and Y is the dependent and Y is determined by X, holds on a relation R if for any two tuples T1 and T2 in R. So consider there is a relation R which is having some rows, or you can say tuple, which is T1 and T2. So consider if there is any attribute X and if T1 of X is equal to T2 of X, then for any attribute Y, T1 of Y would be equal to T2 of y. So according to the functional dependency, it basically helps us to know the dependencies among different attributes of a table, what is the determinant, what is the dependent, how it is getting determined, and much more things. Now coming to the equivalence of functional dependency. So when we can say that two functional dependency set are equivalent. So two set of functional dependency, consider first set is F, second set is G, are equivalent if the following conditions hold. So the first condition is F implies G. Basically it means F covers G. So every functional dependency in G can be derived from F. So consider if there are two functional dependency of F and G and there is a functional dependency in F that can be derived in G, then we say that this is equivalent. And same implies with G as well. So G implies F. Every functional dependency in F can be derived from G. So every functional dependency in F can also be derived by G. Then we can say that these two relations are equivalent. So if both conditions are true, then we say that F and G are equivalent. So consider there are two relation F and G which is having some functional dependency. Consider here it is A determine B and here it is B determine A. So in the equivalence we check that if this particular functional dependency and this particular functional dependency are equivalent among each other. So for that first we will see that if F can cover G, then we will see that if G can cover F, and if both of them holds true, then we can say it's equivalent. We will understand more from the example. So these are the steps on how we can find if two functional dependencies are equivalent or not. So the step one is we have to compute the closure of both of the sets. So consider if there are two sets of relation F and G. So we have to find the closure of F and G, basically all the attribute closure which is present there. Now the step 2 is we have to ensure that every functional dependency in set 1 is in set 2 closure. So consider if we have two relation F and G and we have functional dependency as A determine B and here we have the dependency as B determine A. So we'll take the closure for them. So for F closure we will have the closure of A and B, and for G closure again we will have the closure of A and B. So what is the closure of these two? So now here A closure gives us A and B, and here B closure gives us only B. Coming to this functional dependency, A closure gives us A only and B closure gives us B and A. So we have found out the closure of both of the sets. Now we have to find that every functional dependency in set 1 present in set 2 closure. So what we will do is we have to see that if this A determine B holds true for this particular equivalence relation. So what we will do is we will go to the G closure and we will see for A. A can only determine A can't determine B. So we can say that this particular relation are not equivalent. Consider if this holded true, then we have to see that every functional dependency in set 2 is having in set 1 closure. So for every functional dependency in set 2, that is A and B, we have to see this particular closure which is present in the last set, and then we have to see that if this functional dependency is holding true or not. If you are getting confused, don't get confused, we will see for this from an example. Now the step 4 is if both the subset check pass, then set 1 and set 2 are equivalent, because the set 1 functional dependency is holding true for set 2 closure and set 2 functional dependency is holding true for set 1 closure. So let's understand from an example. Consider that there are two functional dependency, one is F and one is G, and these are the functional dependency A determines B, B determines C, and in the G it is A determines C and A determine B. So we will follow the steps and then we will compute if these are equivalent or not. So the step 1 is we have to compute the closure of both the sides. So here we can see that there are 3 attributes A, B and C, and here also there are 3 attributes A, B and C. So we will find the closure of all the attributes in F. So first we will find the A closure, so A can determine B, so there will be A, B and B can determine C, so it will be C. So A closure will be having A, B, C. Now coming to B closure, B can determine itself, so B can also determine C, so it will be B, C. Now coming to C closure, so there is nothing with C is determining, so it will only determine itself, so it will have these. Now coming to the closure of G attributes, so A closure will have A, then A can determine C, A can determine B. Now coming to B closure will be only having B because there is no B as a determinant. Coming to C closure, C can only determine itself because there is no C as a determinant. So we have found out the closure for A, B, C for all these two sets. Now we have to ensure that every functional dependency in set 1 is in set 2 closure. So consider for this functional dependency A determines B. We have to come to set 2 and we have to see that if in particular A closure, do we get B or not? Then we can say that this particular one is equivalent. So let's see. So in A closure, we can get B. So we can say that this particular dependency holds true for the equivalence relation. Now coming to B determines C. So we have to check for the determinant, that is B. So we have to check the B closure here. So here B closure is only having B. B closure is not having C. So we can say that this particular functional dependency is not holding true for this case. So for now we can say that every functional dependency in set 1 is not present in set 2 closure. Now let's see the reverse. So here the functional dependencies are A determines C and A determine B. The determinant here are A. So we have to check for A. Is A determining C? Yes, we can see that A is determining C. So this one is holding true. Is A determining B? Yes, we can say A is determining B. So these both are holding true. But this one is not holding true. So we can say that F and G are not equivalent because B determines C is not implied or covered by G. So what we have to do is first we have to find the closure. Then we have to do a cross. So what we have to do is, if we have to check for any functional dependency in G, we have to check for the closure of F. And if we have to check for any functional dependency in F, we have to check the closure for G, so that we can conclude that these relations are equivalent. Now what is this minimal cover of functional dependency and why do we even need it? So it is a simplified version of the original set of functional dependencies. It helps us to remove redundant functional dependency. So consider if we have a functional dependency A determine B, B determines C and A determines C. So here we can see from the rule of transitivity, we can conclude that A will determine C. So do we need to have a redundant functional dependency which tell us about this? No, right? So we can remove the redundant functional dependency because from the existing functional dependency, this particular functional dependency could be derived. So it helps us to remove the redundant functional dependency. Coming to the second point, it reduces the complexity of functional dependency. So lesser the functional dependency, the complexity is also reduced. So we can say that it helps us in reducing the complexity. Third is it ensures that there are no unnecessary dependencies which can lead to anomalies in database operations such as insertion, deletion and updation. So from this functional dependency, consider A determines B. If A is a candidate key, super key, then there are very less anomalies. But if A is a non-prime attribute, then there are many anomalies which are introduced in the database. So it ensures that there is no unnecessary dependencies and the anomalies are also lesser. Now let's see that how we can find the minimal cover of a functional dependency. So step 1 is we have to decompose the functional dependency, that is RHS. If there is X determines AB, then it can be written as X determine A and X determine B, so that we can know that which all functional dependencies are redundant. So from the rule of decomposition, we have learned that if in RHS there are two set of attributes or a combination of attributes, that can be decomposed in a way X determine A and then X determine B. But it doesn't happens with the LHS because LHS is a part of candidate key or key which determines this particular attribute. Dependent can be broken down, but determinant can't be broken because that combination is determining this particular dependent. So we can broke the dependent. So here A and B is broken into X determine A and X determine B. Now coming to step 2, so we have to remove the redundant functional dependency. Now how we will find that which functional dependency is redundant? So first is make a new functional dependency set excluding the one you feel is redundant. So consider if there are 3 functional dependencies which are present, A, B and C. For now you can consider this or you can consider this as well, A determine B, B determine C and C determine D. So what we will do is consider right now I am feeling that this particular functional dependency is redundant. So what I'll do is I'll make a new functional dependency set which will be having only B determine C and C determine D. Now second step, I'll find the closure of LHS from the rest of the functional dependency and see if it determines all the attributes of table. So what I'll do is I'll find the attribute closure of this particular LHS A closure and then I'll see if this is getting determined from these particular functional dependency which is existing. If this happens, then we can exclude this functional dependency. If this A closure does not have the attribute which is getting determined, then we can say that this one is not redundant. So if yes, you can remove that. If no, then jump to the next one. So now we can go to B determine C. We can make a new functional set which is having A determine B and C determine D, and then we can take the closure of B and we can see that if from these two functional dependency B is determining C or not. If it is happening, then we can exclude this. If it is not happening, then we have to include this. Now the step 3 is we have to remove the unnecessary attributes from LHS. So earlier we removed the unnecessary attribute, or you can say we have decomposed the attributes of RHS. Now we have to also remove the unnecessary attributes from LHS. Consider if there is AB determining X. So we have to see that if any of the attribute is unnecessary, like this alone can determine all the attributes in the functional dependency, so this could be ignored. If this alone can determine all the attributes in the given functional dependency set, then this could be ignored. So we have to see that if the determinant is a super key, it can be reduced to a candidate key. So consider if AB is a super key, so candidate key is basically a minimal version of super key. So we have to see that if this version of super key can be minimal, and we can get the candidate key. So we can see that if B alone can determine all the attribute, or if A alone can determine all the attribute, and then we can remove this. So candidate key is basically a minimal super key. So let's understand from an example. So consider we have to find the minimal cover of the functional dependency A determines BC, B determines C, A determines B, AB determines C. So let's follow the step. So this step 1 is we have to decompose the functional dependency RHS. Basically we have to decompose the dependent, where if X is determining AB, we can write it as X determine A and X determine B. So let's see if there is any combination which is present in the RHS. So yes, here we can see that A is determining B, C. So we can write it as A determine B, A determine C. Now coming to here, so RHS is not having two attributes, so we can skip this. Coming to here, dependent is not having two attributes, we can skip this. Coming here, there are two attributes or combination of attribute, but it is present in LHS, and we have to see for RHS. So RHS, there is single attribute. So now the functional dependency set would be A determine B, A determine C, B determine C, A determine B, and AB determine C. But here you can see that A determine B is occurring twice. So we can remove that as well, because this is just a duplicate functional dependency. So the final one will be A determine B, A determine C, B determine C, and AB determine C. So the step 2 is we have to remove the redundant functional dependency. For this, we have to make a new functional dependency set excluding the one you feel is redundant. So we'll go one by one. First, we feel that A determine B is redundant. So I'll write it A determine B, for now we are thinking is redundant. So we'll make a functional dependency which would be excluding this. So if I exclude this, I'll be left with A determine C, B determine C, and AB determine C. This is my new functional dependency set. Now we have to find the closure of LHS from the rest of the functional dependency and see if determines all the attributes of table. If yes, you can remove that. If no, jump to the next one. So first we will find the closure for this LHS, that is A. So A closure here will give me A determine C, so C will be there and nothing else. A can determine itself. So A closure is giving me A and C. But since A closure does not have all the attributes, we shouldn't discard this. Since A closure is not giving me all the attributes, we shouldn't discard this, because right now it's not identifying all the attributes. Now we are considering A determines C is the redundant one. So we will have this A determines C. So the new functional dependency set would be A determine B, B determine C, and AB determine C. Now we have to find the closure for the LHS, that is A determines C. So A closure. Now here A will be giving me A will be giving me B, and B will be giving me C. So now A closure is determining all the attributes which is present in the table. So A determine C can also be determined from A determine B and B determine C. So since A closure is having all the attributes, and we can discard this. So we will be discarding this from the final functional dependency set. So now we are left with only A determine B, B determine C, and AB determine C. Now coming to third, B determine C. So now for B determine C, since we have discarded this, we will be only having two functional dependency, A determine B and AB determine C. So A determine B, AB determine C. Now we'll take the closure of the LHS for the functional dependency which we are discarding. So B closure will be having only B. So since B closure does not have all the attributes, we shouldn't discard this. If B closure would be having all the attributes, then it would definitely define C. But since it is not having all the attributes, this particular dependency can't be discarded. So we will not discard this. Coming to the final functional dependency, that is AB determine C. So for AB determine C, we will discard this, and we will have new functional dependency set as A determine B and B determine C. So A determine B, B determine C we are having. So we'll take the closure of LHS, that is AB, and AB closure gives me A, B, and B will give me C. So since AB closure is having all the attributes, we can discard this as well. So we will discard this also from the final result. So from the final result, we can say A determine B and B determine C is the minimal cover for this particular functional dependency. So in this way, we find the minimal cover. So here you can see that we don't need to go to step 3 because we have to remove unnecessary attributes from LHS, but in LHS there is only one attribute. So we don't need to go for step 3 where we are removing unnecessary attributes. So first we will start with re-revising some older concepts. What older concepts we are re-revising here are databases, database management system, types of databases, now why SQL is coming into picture, and much more things. So firstly we will start with databases. What is database? So database is basically collection of data. Now consider an example of a student database. Now what do you think in this student DB? What all things would be there? So there would be data related to the student, right? So there are some data which is related to the student. Now coming to DBMS. What is DBMS? DBMS is a software application which is used to manage our data. So in the student database, there are some data which is present. Now what if I want to do some manipulation in that data? Consider that I am a student, my age is given there as 19, but tomorrow is my birthday and I am being 20 tomorrow. So I want to update my age from 19 to 20. So what I'll do? I'll do some manipulation, I'll do some query which will be helpful in updating that data into the student database. So DBMS comes into picture there. Now understanding how a user interact with DB, or you can say database. DB is a short form which is used for database, and I would be using DB so much time in the video, so please don't get confused. DB stands for database. Now here is a user. Now user wants to interact with database, but would the user be able to interact with database directly? Just think once. No, it won't be able to interact with database directly, because again, as you have learned that if we want to interact with computer, or if we want to interact with machine, we need to interact with them using the binary language or the binary codes. But we don't know that for A what is the binary code, or for B what is the binary code. So we choose a programming language, we do the coding in that programming language, and that is then compiled to the machine code, and which is understandable by the computer. So in the same way, if a user want to interact with database, he or she would be needing a software layer or a software application which would be helpful in decoding all the things student want to do a query or a user want to do a query, and that would be finally executed on the database. So basically, user goes through a software layer, or you can say a software application is being used. So a software layer here is being used. So user adds some queries in that software layer or in that software application, and then from that software application, user can query into database, do some manipulation and different things. So here what happens is there is a user, he or she will use a software application. Now this software application may be using some programming language. And using this programming language, we will make some queries which will give us the required data or update or insert the required data. Now coming to databases. So database is a collection of data. Databases are of two types. First is relational database and second is non-relational database. In SQL, mostly we deal with the relational databases, that is databases which is in a tabular format. So relational databases are databases which use tables to store the data. So relational database mostly use the tabular format to store all the data. If there is a student database, that would be having a table which would be having all the details about the student. Now the examples of relational databases are MySQL, Oracle and MariaDB. Coming to non-relational databases. So non-relational databases are also called as NoSQL databases or NoSQL databases. Now what is non-relational databases? Databases in which data is not stored in tables. So in this database, that is relational database, data is stored in form of tables. But in non-relational databases, data is not stored in form of tables. There might be some hashing techniques or there might be some storage optimization techniques using which the data is being stored. And the most famous example of this is MongoDB. Now we are starting with SQL, but the very first question be why we are reading SQL or why we are knowing about SQL, what is the use of SQL? So we need a language to interact with databases. As I told that there is a user, he or she is using a software application, and using that software application, he or she is interacting with database. Now this software application would be needing a language. You can say a programming language using which we can query into the database. So we need a language to interact with databases. So we use SQL to interact with databases and do some CRUD, that is create, read, update and delete operations on the database. Now you might have heard the term MySQL, and right now you are hearing the term SQL. So what is the basic difference between MySQL and SQL? So let's understand. MySQL is basically a relational database management system that uses SQL as a query language. So what is MySQL? MySQL is basically a relational database management system that is a software application which use SQL, that is structured query language, for querying purpose. So SQL is a programming language which databases, and MySQL is a software or RDBMS which is using SQL as a query language. So this is the basic difference between MySQL and SQL. Now in the further videos we will be knowing about the history of SQL, how we can make queries using SQL, how we can install SQL in our system, how we can make some connections, how we can install the server, how we can install the workbench, and much more things. So firstly, we'll start with the history of SQL. Where this SQL originate from, who made this, and you have also heard the word SQL. Many people call it SQL, many people call it SQL. So what is the reason behind that? So SQL was originated in 1970s from IBM research on relational databases. So basically on relational databases, there is a querying language which is used, or there is a programming language which is used, that is called as SQL, which is structured query language. Now it started as SQL. So SQL stands for Structured English Query Language. So earlier it was named as SQL, which stands for Structured English Query Language, but later it was renamed to SQL due to some trademark issues. So many people call it as SQL, many people call it as SQL. Sometimes I also call it as SQL, sometimes I also call it as SQL. So both are the same things. It was just because of trademark issue the name was changed. So earlier the name was Structured English Query Language, and now the name is Structured Query Language. Now let's start with what is SQL. So SQL stands for Structured Query Language. SQL is a programming language that is used to communicate and manipulate data in the databases. So let's consider an example of a student database. So there is a college. In college, there are many students. Now consider that one student gets shifted from one place to another. So he or she may needs to update their address in the student database. So that updating or that manipulation of data is done via SQL. Now SQL helps user in performing the CRUD operations, that is create, read, update, and delete operations on database. Now let's understand how SQL actually helps us. So SQL allows user to perform a variety of tasks related to databases. Now the very first point is retrieving of the data. Extracting precise information from a database through queries. So one can use certain queries to extract some information about a student. So what happens in class? We usually go to the class teacher or the class monitor and we ask that tell me the details about a person whose roll number is 42. I want all the details of that particular person. So he or she would be able to give me. But on a very large scale, if I ask someone to give me all the details about an employee whose employee ID is 123, so he or she needs to make a query into the database and retrieve all the information and provide it to me. Now the second one is manipulation of data or manipulating the data. So adding, modifying, or removing records within a database can be also done via SQL. So adding some data, consider a new student's taken admission, so his or her data needs to be added. Modifying, consider a student is shifted from one place to another, so his or her address need to be modified. And deletion, consider a student leave the college, so his or her data needs to be deleted. Now the third point is defining the data. So creating and adjusting the structure of database, including tables, views, and indexes. So there might be a possibility that we need to create some new databases. We need to adjust some values or some views or indexes in the database. So that also we can do via SQL. Now the fourth and final one is controlling the data. So managing databases access by granting or revoking permissions. So again, if there is a database of student, you can't allow anyone to make a query into the student details. There might be some permission which would be given to a person that yes, you can at least access the student data. You can at least access the teacher data. So there are some permissions which is provided to an individual, and there are some permissions which is also removed from a particular individual when he or she leaves the institution. So all these controlling of data is also done via SQL. So this was all about what is SQL, how SQL helps us. In the next particular video, we would be starting with the installation of SQL. First, we would install the server, and then we will install the visual tool, which would be really helpful for us to make the queries. So before starting with the MySQL server and MySQL workbench, I want you guys to know a basic concept. So in the last video, I told that there is a user. And if the user wants to interact with database, he or she will use a software application using which he or she can interact with the database. And in this software application, he or she can internally use a language which could be very easy for a user to interact with the database. Now in the last video, we talked about SQL. So SQL is a query language that is called a structured query language, which is helpful in CRUD operations, that is create, read, update and delete operations in the databases. And we also talked about MySQL. So MySQL is a software, or we can say MySQL is a relational database management system. Relational basically means whenever the data is stored in the form of tables. So MySQL is a relational database management system which uses SQL, that is structured query language, for querying purpose. Now, have you ever thought that, okay, we are talking about the user who is making some calls to the DB, but where this DB is stored, where the DB physical existence lies? So DB is somehow stored in servers. So the first MySQL server here comes into the picture. So basically we need a server where our databases would be stored. So firstly we will install the MySQL server. So database server where data is stored, managed and accessed. So we will first start with installation of MySQL server, and then we will proceed ahead with the MySQL workbench. Now what is MySQL workbench? So MySQL workbench is a visual tool which is used for database design, development, administration and management. It provides a user interface to interact with the MySQL server. Now we have set up a server. In that server our database lies. Now how we can make some queries, where we can write the queries. So we need a UI to write that queries, right? So there are two ways in which we can do so. So first is command line. Whenever we have established a server connection, we can use the command line to make databases, do some CRUD operations on the databases. But if you want a very neat and clean way, in a UI you are giving queries and you can see that tables are being created, some data are being inserted, so we can use a visual tool for the same. So in this particular video, we would be learning about the MySQL server and MySQL workbench, like all about the installation process of the same. So firstly we will install the server. So first what we need to do is we will go to the MySQL official website, that is https://www.mysql.com. Then we will go to the downloads. Then we will select the MySQL community version at the bottom of the page. We will choose the MySQL community server. We'll select the version and we'll click on download. And then we will follow the instruction. Set the root password. Why this root password we need to set? So whenever you are establishing a connection on the server, you need to provide a password for that connection. So whenever you are making a new connection, like you are making 10 or 11 new connections, so you need to give that password to the server for you to make a new connection. So this password would be asked while creating a new connection. So let's see from the website itself. So this is the website for the MySQL. So here you can see, you can find this downloads tab. You can click on this download tab. And here at the very bottom, you can see MySQL Community GPU downloads. That is the community version download. Now here you can find the community server as well and the workbench as well. The server and the UI where we will be writing the queries. So we will first click on the MySQL community server. Right now I am using a Mac OS. If you are using Windows, the configurations may differ. So you can see the configuration of your system and download accordingly. So I'll just download this DMG file. So I'll just click on download and I'll click on no thanks, just start my download. So it will just start my download. Earlier I have already downloaded this MySQL server. So this is the procedure you need to do. And then when you are about to install it, it will ask you for some permissions. You can just accept that permissions and you can provide a root password, which would be helpful when you are establishing a connection. And in the same way, you can go back and you can download this MySQL workbench. So here also you can give the operating system and OS version, and here you can click the download button. So both of these things would be downloaded on your personal laptop or computers. So this is the way we can install MySQL server and MySQL workbench on our personal PCs. So I already have MySQL workbench. Let me just show you how it looks. So here you can see that MySQL workbench has opened. Here we can put some queries. Here are some management instance and performance tools. Here you can see context, help and snippets. And here you can see the action, response and everything. From the next video, we will try to create some databases and tables inside the databases. So SQL commands are divided into different categories based on their functionalities. So according to the functionality, SQL commands are divided into different categories. Let's have a look. So the first one is DQL commands, that is data query language commands. So from the word itself, it's very clear, data query language. So any command which is helping us to do some data query, that commands comes into the DQL commands. The second one is data manipulation language commands. So any command which is helping me to do some data manipulation, like inserting some data, deleting some data, updating some data in the database. So all these commands are helping me to do some data manipulation. So that is why they are coming under the DML commands. The third one is data definition language commands. So again, from the word itself, it's very clear, data definition. So any command which is helping me to define the data, to define the structure of the database, or to define the schema of the database, all those commands comes into the DDL commands. The fourth one is data control language commands. Now again, from the word itself, it's very clear, data control. So any commands which is helping me to give some control to the data, like accessing the data, revoking the permission from accessing the data, or granting the permission to access the data, all those commands comes into the DCL command. The fifth and final one is transaction control language commands, that is TCL commands. So any commands which help me during a transaction, like consider that I'm withdrawing money from ATM or I'm making an online payment. So all those commands which comes into picture while doing a transaction in a database comes into the TCL commands. So these were all the categories of commands, SQL commands based on their functionalities. Now let's look about each and every command in detail. So the very first command is data query language commands, that is DQL command. Now DQL is used to retrieve the data from the database. So any command which is helping us to fetch the data from the database or retrieve the data from the database, that comes into the DQL command. Here you can see command which is used is select. So consider that I want to get the details or I want to fetch the details of a student who is in class 2 whose roll number is 3. So what I'll do, I'll make a database query in which I'll use the select command, and in that I can fetch all the details about a student who is in class 2 and having a roll number as 3. So this select command would help me to fetch the data or to get the data from the database. The second one is data manipulation, that is DML command. So DML is used to manipulate data stored in the database. So again, the same example, consider that there is a college database. In that college, a student takes an admission. So we will insert the data of that particular student. Consider that that student is promoted from semester 1 to semester 2. So that we need to update in the database. So updates comes into picture there. And consider that student has graduated from the college. So we need to delete the data of student from our database, college database. So we will be using this delete command for the deletion purpose. The third one is data definition language command, that is DDL command. Now DDL is used to define the structure and the schema of the database. So the schema of the database basically means, like whenever we provide a schema of the database, we give an overview like what is the database name, what all attributes or columns are there in the database, what is the primary key, and etc. things. So we basically provides a structure or a schema of the database. So the commands which we can use is create. Create usually helps us to create tables or create databases. Alter command. Alter command is used to modify an existing database or modify an existing table. Drop command. Drop command is basically used to delete the entire table from the database. Now truncate. Truncate command doesn't delete the entire table. It deletes the data which is present in the table. And rename command is used to rename a table. So all these commands comes into the DDL command, which is indirectly or directly affecting the schema or the structure of the database. The fourth one is DCL commands, that is data control language commands. Now DCL deals with the control and security of data within the database. Commands are grant and revoke. So grant, we are granting some permission. Revoke, we are revoking some permission. So again, we are taking the example of the same college database. Now in the college database, there would be student table, there would be teachers table, there would be some staff table, there would be principal, director, all those details in that particular tables. Now I, being a student, I can't see the teacher details or the staff details. I can only see the details about myself. Teacher can only see the details about the student. So we grant some permission or some security is there so that we can control the access of data. So teacher can access the student data. Student himself or herself can access only their data. So such type of commands which help in that purpose, like controlling of the data or security of the data, comes under the DCL, that is granting and revoking. The final command is the TCL command, that is transaction control language command. Now TCL is used to manage transaction within a database. The commands which comes into picture here are commit, rollback, and save point. Now why this TCL command comes into picture? So you have seen most of the time that whenever we are doing an online transaction, we do the online transaction, we pay the money, we give our PIN. The money is somehow deducted from our bank account, but the transaction is not completed. So in that case, what happens is that money is credited back to your bank account within 3 or 4 working days. So all those things, all that transaction which is happening inside a database, the commands which are helping us to do that transactions comes under the TCL commands. So this was all about the types of SQL command in this particular video. I hope you like this video. I thought to start with the creation of database, but first you need to know what does this create command means. In which category does this create command lies? So that is why I thought to cover these types of SQL commands first and then proceed ahead with other videos. So before starting, let's revise some older topics as well. So what is database? Database is basically the collection of data. Now database is divided into 2 types. First is the relational database, and second is the non-relational database. Now what is relational database? Relational database are the databases in which the data is stored in the form of tables. And all the tables have some relation between them. There is some interrelated data. What is the non-relational databases? So a database in which the data is not stored in the form of table, rather it is stored in the form of key value pairs or something else. So this is the basic difference between relational and non-relational database. As of now, we would be dealing with the relational databases. So consider a scenario, there is a user. Now user wants to interact with the database. How a user can interact with a database? So a user can't directly interact with database. What a user can do is, a user can interact to the database using a software. So using a software, a user can interact with database. Now what this software is called? This software is called as DBMS, that is Database Management System. So any software which is helping us to manage our data is called as Database Management System. Now I told that we are dealing with the relational databases. So we would be using RDBMS, that is Relational Database Management System, for our purpose. So example of RDBMS is MySQL, which we would be using as a software. Now we have got the software, but we need to make some queries into the database. Like if I want to do some insertion, I want to do some deletion, I want to do some update in the values. So I have to tell the database ki, okay, this is the value I want to insert, this is the value I need to update, this is the value I need to delete. So for that purpose, we use SQL, that is Structured Query Language. So it is basically a programming language which help us to make some queries into the database. Like consider that there is a new student which is coming into my college. So all the details about that particular student would be inserted into the database. Consider that there is a student who has left the college. So all the particular data related to that student would be deleted from the college. Consider that there is a student who has got his address changed. So that particular field would also be updated. So all these operations, like the manipulation operations like insertion, updation, deletion, we can do using this SQL programming language. Now coming to the database design. So what is this database design and how is this important? So consider a use case that I have been given, that I have to design a database for student. As of now, I know that I have to design a database for student, but do I know that if I design a database for the student, what would be the tables inside that particular database? As of now, I only know that there is a student database, I have to create that student database. But do I know that what all tables would be there in that particular database? What all domain constraints would be there for that particular table? Domain constraints you can understand in this way ki, okay, there is a field called as name, there is a field called as age. So age would be taking some integer values, name would be only taking character values, age is something which should never be null. So some rules should be there. So I don't know that what all constraints should be there. Then again, I don't know about the primary or foreign keys. So keys help us to uniquely identify records in a table. So I can uniquely identify a record for a particular person in a table. So I don't know about all these things, the constraint, the keys, the tables. Only thing which I know is I have to create a database. So in the database design, what we do is, whenever we are given a use case that we have to create a database, we are also provided with the schemas. So what is schema? So whenever we are giving any table name or the database name followed by all the attributes which is present there, we called it a schema. So here you can see that there is a student schema, right? With all the attributes which is there is student name, student roll number. Here you can also see that there is a teacher schema, which is having all the details about the table name, that is teacher, the characteristics or the attributes, that is table name and teacher ID. And here you can see that we are taking the database as school. So we have taken the database as school DB we have taken as of now. In the school DB, there are two tables. First is the student table. Second is the teacher table. Now when we create a table, there are multiple number of rows and multiple number of columns. So these are called as rows and these are called as columns. But in databases, we call columns as attributes or characteristics. So basically attributes are the characteristics of a particular entity. Like consider that there is a student database. Now that particular student database is having some of the tables like student course or student address details. So there are two tables in that student database, course and address details. So both of them would be having some of the attributes, like course is having some of the characteristics such as course ID, course name, like all the things about the course. And the address would also be having all the details about the address like street, flat number, pin code, everything, right? So all the attributes or the characteristics which is present, we insert in the column, and all the particular record about that particular student is inserted in the rows. So basically these all are the characteristics or the attributes, and this is the table name. So you can see S name, student roll number, teacher name and teacher ID are part of attributes or the characteristics of that particular entity or that particular table. So now we are clear that we have been given a college database or a school database in which there are two tables, student and teacher. Now in that student table there are some attributes, in that teacher table there are some attributes. So we have done a basic designing of our database. Now let's move ahead with the creation of database. So whenever we are creating a database, we create a database in a server. So what we do is, first we establish a server connection to create a database. So once we have established the server connection, we can create databases. Now the first question which will arise in your mind is, can we create only one database in one server, or we can create multiple databases in one server? So the answer is, we can create multiple databases in a single server with a different name. Yeah, so the name shouldn't be same. With a different name, we can create multiple databases in a single server. So consider that this is a server 1. In that server 1, there are two databases, database 1 and database 2. So there are two databases which is created as of now in server 1. Now in databases also, the second question is, in a database, can we create only one table or multiple table? So the answer is we can create multiple tables in a single database. So you can see that there is a school database. In that particular school database, there is table 1 which is course, and there is table 2 which is fees. And in this hospital database, there is a table which is patient. So in a single server, there could be multiple databases. In a single database, there could be multiple tables. So this happens while creation of database. So when you have established a connection in a server, you can go ahead and create the database. In that particular database, you can create some tables as well. So there is no restriction on the amount of creation of databases or the amount of creation of tables. Now let's start with the creation of database. So there are some steps which we should follow while creating a database. Let's have a look on them. So the first step is choose a DBMS, that is choose a software. As I told earlier that if a user needs to interact with database, he or she needs a software. So we would be choosing a software. As I told earlier that we are using relational databases, or we are dealing with relational databases as of now. So we will be choosing a RDBMS, and that is MySQL for now. Now the second one is connect to the server using command line or a graphical user interface. So now I have installed the software, I have the software. Now I need to establish a connection in the server where I would be making the databases. So that I can do in two ways. Either I can go to the command line and establish a connection, or I can establish a connection using GUI or user interface which I am having in my PC. So mostly the command line is not covered here. So you can go ahead and have a look on all the articles which is presented, how on the command line we can establish a server connection, we can create a database or insert the database. The commands remain the same, but just there are 2-3 more steps extra. So the third one is create a new database. So there is a command we need to execute for creating a new database in the UI or the user interface which we have downloaded for executing all the SQL queries. Now the fourth one is, once the database is created, you can use the use statement to create tables in the databases. So again, going back, as I told that in a server there could be multiple databases. So how the server would know that if I want to create a table, in which particular database I want to create a table? So for that case, what we do is we use the use statement, use followed by the database name. Once I execute this particular query, my server will be known that okay, in this particular database, now what all actions are being done is being done in that particular database, like insertion, deletion, updation, anything. So I can use the use statement to tell the server that as of now I am working on this particular database. And the fifth and the last step is create tables and insert data. So before moving forward with the SQL commands, I just want to let you know that SQL commands are super easy to understand because SQL commands are very similar to the English statements. Consider that if you want someone to create a picture of yours, like create a drawing of yours, what you will say, can you please create a drawing of mine? So you say create a drawing, right? In the same way, if you want to create a database in SQL, you say create database followed by the database name. So it's just like the simple English language which we use in day-to-day life. And whenever I say someone that create a drawing of myself or create a picture of myself, I'll just end the statement with a full stop. Here we end the statement with the semicolon. So it's just like a statement which is ended by a semicolon. So to tell the server or to tell the database that this particular command is being executed and the next command is in next line or whenever the next semicolon is found out. So we use the create database statement to create a new database. So we generally use the create database followed by the database name statement to create a new database. As I told, again, it's very similar to the English language, like create a database. So create database. These commands are not case sensitive. So what does this case sensitive means? Consider that if I am executing create database followed by a database name, consider student. If I am executing this command in uppercase and if I am executing this command, the same command, what is happening? Okay, so create database student. So if I am executing this command in uppercase or in lowercase, both will give me the same result. So this is not case sensitive, like we can either use the smaller cases letters or the uppercases letter. So for now, let's go with the uppercases letter because there would be a notion we would be following for all the particular queries. So let's follow the uppercase one. So we will use this particular command, that is create database name. So let's go to our UI and let's learn that how we can create a database. So I'll be opening my MySQL workbench. So here you can see in MySQL workbench, by default, there is a connection which is established, but I want you all to learn that how we can establish a new connection as well. So we'll just click on this plus icon. Once the plus icon is created, we'll give the connection name. Just give it as SQL for now. And here we can give the password, which was asked while we were installing the MySQL workbench and server. So I'll just provide the password here. And once I have provided the password, I can click on OK. So you can see a new server connection is established here. So once I'll open this server connection. Now here you can see that there are many tools which is present. So let me just familiarize you with all the tools which is present and then we will go ahead with the query. So here you can see that there is an administration tab and here you can see that there are some of the instances and management status which is present. So this basically deals with our server connection if you want to make a new connection, if you want to end that connection, and other things. So there is a schema tab. In this schema tab, you would be seeing all the databases you have created, all the tables you have created, the primary key, the foreign key, the constraint, everything in the schema tab. By default, you can see that there is a SYS schema which is already present. This is of MySQL Workbench. So basically the database administrators have this already created to see the performance, how the performance is going. There is a performance schema also present here which is present in this SYS. So we'll not touch this SYS, we'll just create a new database here. And here you can see that there are some icons. So this icon would help you to create a new SQL file. So if you want all the queries to be in new file, or if you are creating new file, or if you are creating multiple databases or working with multiple databases, you can create new files and work on that particular database. Here you can see that there are two run commands. Like if I am writing any query, I have to run it, right? So for that particular query, if I have to run it, there are two tools. So the first tool runs everything which is present in the file. Like if there are 16 or 17 SQL statements, it will execute all the SQL statements which is present. And the second one is run the selected one. So if I select any of the SQL statement, that only would be executed, not the entire file. So let's start with our first query to create a database. So I'll simply give the statement create database followed by the database name. As of now, let's give it school. And I'll just execute this line on selecting it, and I can use this particular run button. So here you can see that there is a success. So a database with the name school is created, but you won't be able to see it here. So to see it here, you have to do a refresh. And once you refresh, you can see the database with the name school is created. As of now, there is no tables in that particular database because I have just created a database. So in this way, we can create a database. Now, if you see here, I have also written it also to avoid errors. We can use this command create database if not exists database name. So why is this needed, create database if not exists? So let me just show you. So I have written this command create database school. A database with the name school is already created into my system. Consider I am running this command again. So what it's showing? It's showing me an error that a database with the name school already exists. So what we do just to avoid errors, because errors are something which is like nightmare for developers. So just to avoid errors, what we do is we put an additional check that if not exist. So create a database if it does not exist. So we will use this query create database if not exist, and we'll give the database name. Now if we run the same query, you will see that you are not getting an error. Rather, you are getting a warning message that already this particular database exists. So if you want to create tables in that particular database, you can use that particular database. So right now we are not seeing an error. We are just seeing a warning. So it's better to add this additional check while creating a database. Create a database whenever there is no existing database with the same name. So create a database if not exist database name. So this was all about the creation of database. Now let's see how we can delete the database. So we use the drop database statement to delete a database. Dropping a database means deleting the entire database, including all the tables. So dropping a database means consider that you have a database of student. And in this particular student database, you have two tables. First is the course table, student course table, and second is the student address table. So once you use this drop database command, so what will happen? It will delete the entire database, including all the tables which is present in this particular database, all the data which is present in this particular tables. So it will delete the entire database, all the objects, all the values which is present in that database. So this command is not usually suggested, and if you are a developer, I would surely say that please avoid these commands and don't ever do this command or don't ever execute this command in the prod database, because like that would be a nightmare for you. So always avoid this command, but since we want to know how we can delete our database, this command is necessary to delete our database. So the dropping means deleting the entire database, including all the tables in the data, all the other objects within it. So drop is a DDL command, that is data definition language command. Now these commands are not case sensitive, as I told for the create command. So the command for dropping a database is drop database followed by the database name. So let's see about this command as well. So as of now, I have already created a database with the name school. So let me just delete this database. So I'll do drop database followed by the name, followed by the database name. Just run this. So you can see that we have got a success. So this database is deleted from our schema. So here you can see that the school database does not exist. Now again, in this particular slide, you would be also seeing that I have given also to avoid errors. So do we get errors while deleting that database as well? So the answer is yes. There could be a possibility that in the server there are many databases. You forgot that which database you have deleted, and again you are running the same command to delete that particular database which is already deleted. So it will give me an error. So what we do is we write the command drop database if exist. So the database should be existing, only then delete the database. If the database is not existing, do nothing. So drop database if exists the database name. So let me just show you again. So I have already deleted the school database. Let me again just delete the school database because I'm not aware that what all databases are there in my server. So by mistake, I have deleted the school database and again I'm deleting the school database. So if I again execute this command, you can see I'm getting an error because this particular database I have deleted just 2 minutes back, but I don't remember that I have already deleted this database. This could happen like if you have deleted a database 1 week ago and after 1 week you don't remember that if I have deleted that database or not, and you run the same query. Or consider that you can also run the same query for a database which is not existing in the schema. So as of now, consider that there is a teacher database which is not existing in the schema. And if I run this particular command also, it will show me an error because this particular database does not exist in the schema. So to avoid such errors, what we do is we include this if exist clause so that it will check that delete the database if it exists in the server. So we will use this for the school only. We will use the same command. So drop database if exist, and here I give the command as school. So let me just run it again. So here you can see that we are not getting an error, rather we are getting a warning message that this student database does not exist, it's already deleted. So in some way we are avoiding the errors, we are just getting a warning messages. Now let's see that how we can use the database. So as I told that once we have created the database, there could be many databases in the server. So I have to tell the server that if I have to create any tables or I have to insert any data, which database I am inserting to. So for that we will be using the use statement. So use followed by the database name. We use the use statement to use a database. These commands are not case sensitive and the command is use followed by the database name. So let's see. So again what I'll do is I'll create a database. Let's create a database college. So I'll execute this statement. So it's success. I'll just do a refresh all. So here I can see a college database which is created. Now what I'll do is I'll do just use and I'll give the database name, that is college, followed by a semicolon. And once I run this query is also executed with a success. So now in this database only we can perform all the actions. So this is the use of use statement. Now let's see the next command. Now let's see how we can see the database. So showing a database, we use show databases statement to see all the databases which is present in the server. As I told earlier that in the server there could be multiple databases. Now I want to see that what all databases are there in my server. So what I'll do, I'll just execute this show databases statement which will show me all the databases which is present on my server. So let's use this command as well. So we will just do show databases and I'll just execute this command. And here you can see that all the databases which is present in my schema is shown. Now again, as I told that SYS performance schema is something which is related to MySQL Workbench. The DBA administrator use it to analyze the performance and everything. But here you can see the database which we created college is already shown here. This was all about creation, deletion, seeing all the databases in the server. In the next video, we would be doing the same for the tables, like creating the tables, inserting the data into the tables, deleting the tables and seeing all the data which is present into the tables. In the last video, what we did was we created a database followed by the database name. Let's consider school. And then we used the database to create the tables or insert the data. Now third step, we do the table creation. So let's see how we can do the table creation. So we use the create table statement to create the table in a DB. So once we have used the database, we have told the server that this is the database in which I want to create tables. I'll use this create table statement to create the tables in the database. Now what is the command to create the same? So we give the create table followed by the table name, and then we provide all the columns which should be there in the table. So again, the table is an intersection of rows and columns. So columns tell me what all values should be there for a particular record. Okay, so consider for now we are taking the school database. Now in the school database, consider that there is a table student. So for that student table, there would be some columns, there should be some rows. So student may have characteristics such as student ID, student name, student age. So there are some characteristics or attributes which the student would be having. So we will provide all the attributes, all the characteristics in the column. Now the second one is data type. So whenever we create a variable in programming, what we do is we give the data type followed by the variable name. Like this, int A. So it tells me that A would only accept integer values. In the same way, we provide the data type for all the particular columns in the database, because there could be a possibility that if I don't provide the data type for SID, someone can insert XYZ into the SID, which is not a valid student ID. Someone can insert 1, 2, 3, 4, XYZ which is again not a valid student ID. So I tell that this particular student ID will only be accepting values of the particular data type. So we provide the data type. Now the third thing is constraint. So what is constraint? So constraint is basically a set of rules which we provide to our attributes. So basically whenever we are giving all the attributes, we provide that these are the constraints which are there for that particular attribute. Now in the constraint there could be many things like not null. So if there is a not null which is provided to any of the attribute value or any of the column, that particular column couldn't have any null values. It needs to have some value. So why these constraints are given? Because it helps us to eliminate the duplicate data and the data which is misleading or incorrect data. So the insertion of incorrect or duplicate data is hindered whenever we provide the constraints. So creating a table. So create is a DDL command, that is a data definition language command. Now here the example is given. You can give create table followed by the table name. Let's consider a table name as employee. Here you can provide the first column, that is employee ID, the data type, that is int, and then the constraint, that is primary key. Again the second column name followed by the data type, that is varchar. The third column which is salary and followed by the data type, that is int. Again constraints are not something which is mandatory to provide. You can provide or you can't provide. Like it totally depends on you if you want like some unique values, some not null values in the particular column. Again right now you won't be understanding these terms like primary key, what is varchar, what is int. So as of now just forget all these. Just remember that to create a table, we give the command create table followed by table name and we provide all the columns which should be there in that particular table. So let's just execute this command in our SQL workbench. So this is my SQL workbench. Let me just start with creating a database, then I will create the table inside that particular database. So let's just execute the command to create a database. So it would be create database followed by the database name. Let me give it school. Okay. So let's just execute this command. So you can see that this command is successful. Let me just refresh it here. So our database with the name school is created. Now I'll just let the server know that I am creating all the datas in this particular database. So I'll just use school. And I'll just execute this. So now use school is executed. Now I can create all the tables, all the data in this particular database. Now let's start with the creation of table. So I'll just give create table followed by table name. Let's just take the table name as course. And then I'll provide all the columns which should be there in the course. So let's take CID, course ID, and I'll provide the value as int. Let's take course name and I will provide the value as varchar and I'll give the limit for the number of characters, that should be 50. So let's just execute the statement. So here I've created a table with the name course which is having columns such as CID and having the data type as int, course name having the value as varchar. So let me just execute this. So you can see that there is a successful execution of this particular statement. When you will do a refresh, here in the tables, you can see that one table with the name course is created and the columns which is present in this table is CID and CNAME, which is the course ID and course name. So course ID would only be taking integer values and course name would only be taking the character values. So this is the way we create the table in our databases. Now since we have created the tables in the database, how we can insert the values in that tables? So inserting values into the table. So insert is a DML command, that is a data manipulation language command. Now we use this particular command to insert the values into the database. So that is insert into. We'll give the table name followed by all the columns in which manner we want to insert the values. So if you have provided a data like Raj here, so it will insert Raj here. And if you have provided the address as Pune, it will insert Pune here. So if you don't provide the column name, it will insert in a sequential manner into all the columns. But if you want to insert in like a different fashion, like if you want to insert the first value into the column 1 and the second value into the column 3 and the third value into the column 2. So you need to provide the column names here. So in whatever fashion you are providing the column names, it will insert the values in that particular fashion only. And here you can give the values value 1, value till value n. Now here we can see the example. So here we are inserting values into the employee table we have created. So we'll use insert into the table name employee and then we will give all the columns employee ID, employee name, employee salary, and then we will provide all the values we need to insert, like 1 Raj, the salary is 1200, the employee ID is 2, the name is Rahul, the salary is 1100, the employee ID is 3, the name is Riti, and the salary is 1100. So in this way you can insert the values into the particular table and you can provide all the values which needs to be inserted. So let's see how we can insert the values into our course table which we have created just now. So we'll just execute the command insert into. We'll provide the table name, that is course, and then we will provide all the columns. First one is CID, second one is CNAME, and then we will provide all the values to be inserted. So the first value, let's insert the course ID as 1 and the course name as physics. Let's insert the second ID as 2 and the course name as maths. And let's just execute this. Okay, just there is a typo, so it would be values. So let's just run this command. So once you run this command, you can see this success. So all the values have been inserted with the first course ID as 1, the subject name as physics, the second course ID as 2, and the course name as maths. So in this way, we can insert the data into our table. Now let's see how we can see all the values which have been inserted into our table. So we created the database, we used the database. In that particular database, we created tables, we inserted some data into that particular table. Now we would be seeing that how we can see all the values in that particular table. So to see all the specific values of a column, we can either use the select statement followed by the column from the table name. So it would be select the column name from and the table name. So the table name is and the column name is employee ID. So if I want to see only the employee ID details, I can just use the select the column name from the table name. And here to see all the values from the entire table, we can use select star from employee. So whenever I'll execute this statement select star from employee, it will show me all the records which is present in the table. So let's use this particular statement. So what I'll do is I'll use select star from and I'll give the table name as course. And I'll just execute this. So here you can see that our table is created with CID, course ID and course name, where the values are 1 for physics, 2 for maths. So in this way you can see all the values which is inserted into your table. Now as I told that you can see all the databases which is present in your server, in the same way we can see all the tables which is present in our database. So there is a command to see all the tables which is present into our database. So we can use show followed by tables. So show tables will provide me all the tables which is present in the database. So let's see how we can see all the tables which is present in our database. So we'll just use this show followed by tables and we'll just end it with a semicolon. So in this way we can see all the tables which is present in our current database. So here you can see that there is only one table which is present in our schema, that is course. So in this way we can see all the tables which is present in our database. So here we are taking an example of Instagram database. So let's create a database for Instagram. In this we would create the database, we would create the table, we would insert the data into the table and we'll see all the data which we have inserted into the table. So before moving forward, let's understand some basic concepts. So there is a server on which we generally create our databases. Now on a server there could be multiple databases like DB1, DB2, tilted DBN. Here DB stands for database. Now in this particular database there could be multiple tables like T1, T2, T3, in this also T4, T5 and this as well till EN. So what we understood is in a single server there could be multiple databases and in a single database there could be multiple tables. So the very first step is create a database. So we'll execute this particular query, that is create database. Now here we are using this if not exist clause. Why this clause is needed? There could be a possibility that in a server, since there are many databases, there could be a possibility that two databases is having a same name or we are giving the same name and a database with the name already exists. So in this way we will get an error. So just to avoid that error and get a warning message, instead we use this if not exist clause. So it basically makes sure that create a database only if that particular database does not exist on our server. So this is create database if not exist and followed by the database name. So let's just see our MySQL workbench and there we would be executing this query and learning how we can implement all the things practically and create a database followed by table and then see all the data which is present in the table. So this is the MySQL workbench UI. Here you can see all the output and here we're giving the query. So it is create database if not exist and then we'll give the database name, that is Instagram DB, and we'll just execute this particular query. So once I execute this query, I can see a success here, but in the schema tab I can't see my database. So for that I'll just do a refresh all. So once I do the refresh all, I can see a database with the name Instagram DB is already created. For now there are no tables as we have not created any tables, but a database with the name Instagram DB is created. Now let's see the next step. So in this step 2, we would be using the database to create the tables. Now coming to the same example. So in a server, there could be multiple databases. So a server needs to know that if we are creating table, in which particular database we are creating a table. So to let the server know, we use this use statement. So we'll give the use followed by the database name, that right now I am using this particular database for creation of tables, insertion of data into the tables and much more things. So let's just go to the SQL workbench. So here we'll be giving the command use followed by the database name, that is Instagram DB. And we'll just execute this particular query. So here you can see the success. So as of now, whatever tables we create would be created in this Instagram DB or database. Now let's see the step 3. So this step 3 is the creation of tables into the database. So here is the query for the creation of tables. As of now we are taking two tables. The first table is the user table and the second table is the post table. Now in this particular query we give create table. Again here also we give an additional check. What if a table with the name post already exists? So create table, if not exist, user. So if there is no table with the name user, only then create a table which is named as users. So now here we provide all the columns, or you can call it as attributes or the characteristics of the table. So the first column is user ID, the second column is username, and the third column is email. Then we provide all the data types, that what all values this particular column can hold. So here we are giving the integer value, here we are giving the varchar, or we can say character values, and here also we are giving the character values. So in the third argument we usually provide the constraint. So here we are saying that this particular user ID is now having a key constraint, that is a primary key constraint. That means this particular column user ID can only hold unique values and not null values. So a primary key is a key which helps us to uniquely identify all the records in a table. So if a column is declared as a primary key, so it can't hold any duplicate values. It should always be unique and it should always be not null. In the same way we are creating the table for the post. The query is almost same. Here we have column as post ID, user ID, and caption with the data type as int. Here also int, and here we are giving as varchar. And here also we are giving a primary key constraint for the post ID, that the post ID will always be unique, the user ID will always be unique. So let's just execute it in the SQL workbench. So let me just copy this command and execute it in the SQL workbench. So I'll go here and I'll just paste it and I'll just do a run. So here you can see a success is shown in the output window, but here right now you can't see the table. So for that you have to do a refresh all. So once you do the refresh all, it will show a table with the name user which is created, which is having columns as user ID, username, and email. Now let's do for the second table as well. We will just copy this and we'll just paste it here and we'll just run the query. So here also you can see a success report that a table with the name post is created. Now we'll just do a refresh all here as well. So here you can see a table with the name post having columns such as post ID, user ID, and caption is created. Now in the next step we would be inserting values in this table. So in this step 4 we would be inserting the values into the table. So this is the query we need to execute to insert the values into the user as well as the post table. So we'll just give insert into followed by the table name, that is users, and then we will provide all the columns, that is user ID, username, and email, and then we will provide the values. So 1 would be inserted into the user ID, Riti would be inserted into the username, and email would be inserted abc@gmail.com. So it follows the same pattern which is given here, the insertion. So in the same way the 2 and 3 would also be inserted, and in the same way for the post also insert into table name, that is post, then we'll provide all the columns, that is post ID, user ID, and caption, and here in the values we will provide all the values which we need to insert. So let's just execute this query in the SQL work. So let me just copy it and paste it here, and then I'll just execute this particular query. So here you can see a success report is generated. Again I'll do just a refresh all. So as the data is inserted, we can't see it here. There's a special command to see all the data which is present in the table, which we will see in the step 5. So let's do the same for the post table as well, and I'll just run this query. So you can see the success. So as of now my database is created. I've created two tables inside my database, that is users and post. I've inserted some data into the users and post table. Now let's see if all the data is inserted into the table or not. So in the step 5 you can see all the tables that is present in the database. So first we'll give the query use followed by the database name, which will help the server to know that the next command which is being executed for the Instagram DB, and then we'll give the show tables command. So let's see. So I'll just give use followed by the database name, that is Instagram DB, and I'll just give a semicolon. So the execution is successful, and then I'll give show tables. So this command will show all the tables which is present inside this database. So I'll just execute this query. So here you can see that there are two tables, post and users, which is present in this particular database. So in this step 6 we would be fetching all the values in a specified table. So for the first table we would be executing select star from users, and for the second table we would be using select star from post. So select star help us to fetch all the records which is present in the table. So let's go to the MySQL workbench and execute these queries. So we'll be just executing select star, then from, and then we'll give the first table name, that is users, and I'll just execute this query. So here you can see that all the data which we have inserted is here, that is 1, 2, 3, Riti, Raj, Rahul, and the email. And when we want to fetch the data for the other table, we will be using the same statement, just we will replace the users with the post. So select star from, and here I'll be giving post. So let me just execute this query. So here you can see 101, 102, 103 and all the caption and user ID is present. So in this way we create a database, we use the database, then we create the table in that particular database, we insert the values in that particular table, again we see all the tables which is present in our database, and then we see all the data which is present in both the tables. So before starting with the data types in SQL, let's just understand what was the need of introducing data types in SQL. So consider an example of a company. So in a company, there could be many employees, E1, E2, till En. So there could be n number of employees. As of now, I have told that I have to feed the data for each and every employee in the employee table, which is having columns or attributes as name and age. So I'll start feeding the data of each and every employee in this particular employee table. So consider the first employee is Amit, who is having an age of 27. The second employee is Raj, who is having an age of 28. So first what I'll do, I'll feed the data for Amit. So I'll feed the name as Amit and age is 27. Now in the second, I'll feed the data for Raj. But while feeding the data for Raj, by mistakenly, I feed it 28 in the name and Raj in the age. So there was a reverse order in which I feeded the data. So what will happen whenever I make query, give me the name of all the employees whose age is 27. So what will happen in the age section, it will find out that there is one employee with the age 27, but the second employee is having Raj, which is not a valid value which should be there in age. Like no one's age can be Raj, right? So this is kind of an incorrect data. So it causes a data inconsistency. So what we do, whenever we do a creation of table, so the command for creation of table is create table followed by table name, which would be employee as of now. And whenever we will create the columns for the same, so what we will do is we will give name and then we will provide the data type that this particular type of data a column can store. That is the main reason of introducing data type. So we will give name, then we'll give varchar. So varchar is basically used for storing the string values, and when we will give for age, we will provide it as int. So it will make sure that name is only having varchar values and age is only having integer values. So whenever we will insert data into the table, while insertion only, if we feed wrong data in the columns, it will give me an error. So data types are basically used to specify the type of data that a column can store. So there are numerous types of data types. First is the numeric, second is the character or string, third is the date and time, fourth is the boolean, and fifth is the binary. Now in the numeric data types, there are many type of data types: integer, small int, big int, decimal, float, double. So these all data types help us to store the integer values or the numeric values. In the character and string, there are three data types: character, varchar, and text. These all help us to store the string value or the character values. In the date and time, there is date, time, timestamp. So all these data types are used on the basis of their use case, but this helps us to store the date and time. In boolean, there is a boolean to store the true or false values. In binary, there is a binary, var binary block to store the binary values that could be 0 or 1. So let's see about each and every data type in detail, and let's understand that where the use cases of such data types occurs. So first start with the numeric data type. So the very first one is int. So it is used for storing whole numbers without decimal points. So whenever we want to store a whole number without a decimal point, consider the age. So we always say that age of a person is either 16 years or 17 years. We never say the age is 16.5 years, right? So whenever we want to store a data which is a whole number, we use this integer value. Now int is having this particular range in which all the data could be stored, and it is a signed integer. What does this signed integer means? It means that it can also store the positive as well as the negative values. So the positive and negative values both can be stored in this particular int data type. Second one is big int. So big int is also used for storing whole numbers, but it stored large whole numbers. So the limit here was less, but here the limit gradually increases because it stores large whole numbers. So whenever we want to store a value which is very large, right, so we use this big int. So the third one is float. So float is basically used for storing the decimal numbers. So whenever we want to store the value which is in decimals, we use the float data type. Now the fourth one is double. So the double is used for storing decimal numbers, but again in the float the range was less, but in double the range becomes double. So if you want to store a value like 17.5, you can store it in float, but if you want to store a value like 17.555555555, so you can store that value in double. So it gives more precise value and it gives a less precise value. So if you want to store in a less precise value, or in, you can say, a round off number, you can store in float, but if you want a very precise value, you can store it in double. So basically float and double both are used to store decimal values. Int and big int both are used to store the whole number values. It's just the range which gets increased. So the fifth one is decimal. Decimal is basically used to store some values in which we provide that this is the precision I want in that particular value. This is the scale to which the value should be. So it is used for exact numeric representation. P is the precision and S is the scale. So if I want a value which is having 4 digits after the decimal, so it can help me to get that particular digit. So here you can see there is a command for creating a table and providing each and every data type for each and every column in the table. So in this way we provide the data type type while giving the column name while creating the table. So whenever we are creating the table, we will provide the column name and then we will provide the data type, like what value the column would be holding. So by default, all the numeric data types can have negative as well as positive values, as I told about the int. So int can have positive as well as negative values. This restricts the range. So if we know there is only positive values which is stored, we use the unsigned attribute. So what we do is consider age. So we know that age would always be a positive value. It won't be minus 17 years, right? So I know that age would only hold positive values. It can't hold negative values. So what I'll do, whenever I'll define the age or whenever I'll provide the data type for age, I'll just put this unsigned attribute after int, which will help us to increase the range. So what it will do, it will increase the range to 256 characters. So earlier the range was very less, but now my range is increased to 256 characters. For example, salary can never be negative or age. So salary or age can never be negative. So we provide this attribute unsigned, which says that this particular ID or this particular age or this particular salary would be only holding positive values. It can't hold any negative values. So it helps us to eliminate that negative range and add it to the positive range. Now let's see about the character data type. So there are three data types here: char, varchar and text. So let's see about the char data type. So char basically means character. So whenever we are storing any characters, we can use this char data type. Now here n basically means the size of string. So whatever would be the size of string we would be giving here. So whenever we want to store any fixed length of character strings, we use this char. So the range is from 0 to 255 character, that is A to Z values. Whenever we want to store, we can use this char data type. Now what does this fixed length of character means? So whenever I am giving a column name as char, what it will do is, consider that I have given the size as 50. So it will allocate or reserve 50 blocks of memory. So 50 blocks of memory is allocated or reserved for name. So whenever the first name is feeded, consider the first name is Raj. So I feeded Raj. So what will happen, that these memory spaces are wasted. Consider for second name Riti. So I feeded Riti. Now these memory spaces are being wasted. So these all memory spaces are being wasted and it's not utilized. So it's kind of not a good practice to use char. Rather we use varchar. Now what is varchar? So var here basically stands for variable and char basically stands for character. So whenever we want to store variable character or variable length character strings, we use varchar. Now what will happen varchar? So consider that I've given name varchar 50. So whenever I give name varchar 50, it will not go ahead and allocate a fixed length of 50 characters. What it will do, whenever I'll insert the value, consider Riti. So it will go ahead and it will insert Riti. And all the rest spaces wouldn't be occupied. So it basically inserts the value in a dynamic fashion. So the memory allocation is very good because none of the blocks of memory is wasted. But in char data type, what happens that because it is a fixed length, it will go ahead and allocate 50 blocks of memory. And in that 50 blocks of memory, even if you are using 4 blocks, the rest 46 blocks are wasted. So that is why we usually prefer using varchar, because it is for variable character string. So whenever we will provide any value, it will only take up that particular value and rest all blocks wouldn't be allocated. So the memory consumption is good. The third one is text. So variable length character strings with no specified limit. Here you have to give a limit. Here also you have to give a limit because it can hold only 0 to 255 characters. But if you want to store more characters, or there is no limit to the character string you are storing, so you can use the text. So this is the way we can use this varchar, char or text data type. Create table name followed by the column name, and here we can provide the data type. So the third one is date time data types. Here the first one is date, the second one is time, and the third one is date time or timestamp. Date is basically used for storing the date values in this format, that is year, month and day. The second one is time, which is used for storing time values, that is hour, minutes and seconds. The third one is date time or timestamp, which is used for storing date and time values. So it will give year, month and day followed by the hours, minutes and seconds. So the command which we can use is create table name, and then we can give this created timestamp as the column name, and here we can provide the data type as timestamp. So it will store the values in the format of year, month, day followed by the time, that is hour, minutes, seconds. So this is basically used for storing date and time values. So the fourth one is Boolean data type. In this Boolean data type, there is only one data type, that is Boolean. So Boolean is basically used to store a true or false value. So consider that you are a person, you want to see that if you are eligible for vote or not. So if you are greater than 18, you are eligible to vote. If you are less than 18, you are not eligible to vote. So you are making a column is eligible to vote or not. So in that particular column, there would be only true or false values. So in that particular use case, we can use this Boolean data type. So in the same way, we can use this create table followed by table name. And when we are giving the column or when we are defining the column, we can define the data type as Boolean. So the fifth one is the binary data type. Now in this binary data type, there are three data types: binary, var binary and blob, that is binary large object. So the binary is basically used for storing any fixed length of binary data. So binary data is 0 or 1. So whenever I'll give binary and the limit as 1, so it will only store 0 or 1. In the same way, var binary, basically variable binary, is used for storing variable length of binary data. It is the same what we saw for char and varchar. So char will only store fixed length character data. Varchar will store variable length of character data. So even if I am giving binary and the limit as 2, I can store 0, 1, 0, 0, 1, 0, 1, 1, like without even considering about the memory what is being used. Now the third one is blob, that is binary large object. It is used for storing large amounts of binary data. It is also variable length. So the command which we use is, while creating the table, create table name, we give the column name data, and here we provide blob, that is binary large object, which could help us to store the large amount of binary data. So this was all about this video. I hope you had a good understanding about the data types in depth, and now you understood that why while creating the table we were using the data types, what are the use case of data type where a particular data type can be used. So before starting with keys in SQL, let us understand what keys exactly is. So here I have taken an example of employee table. So in this employee table, there are some columns such as ID, name, age, phone number, which are also called as attributes or the characteristics of the table. And here I have fed some data in the rows, which is also called as tuple in DBMS. Now here I have fed the data for employee 1, employee 2 and employee 3. So ID is 1, name is Raj, age is 27, phone number is given. ID is 2, name is Rahul, age is 27, phone number is given. ID is 3, name is again Raj, age is 27 and the phone number is given. Now there should be a unique identifier or a unique attribute which could help me to identify records in a table or can distinguish between two records or two tuples in a table. So basically employee 1 and employee 2 can be distinguished on a single factor, that is called as key. So keys are basically a unique identifiers, or we can call it as attribute or a set of attributes which help us to uniquely identify records in a table. So in this particular table, ID is something which is unique for every employee, like 1, 2, 3. So we can't see some duplicate values. It is unique for every employee and it can help me to distinguish between two employees. Like employee is Raj, so the ID is 1. This for the second Raj, the ID is 3. So it can help me identify records in a table. Now the second attribute is name. So as you can see, name is not unique for everyone. Two persons can have a same name. Here you can see employee 1 is also having name as Raj. Employee 3 is also having name as Raj. For the age also, age can be again same for different people. Phone number can be different for different people. So here we can see ID is also serving as a key, as well as phone number is also serving as a key. So ID and phone number can help us to uniquely identify records in a table. Now coming to types of keys. So there are two types of key. First one is primary key. So a primary key is a unique identifier for each record in a table. So primary key is basically a unique identifier for each record in a table. So here the key was ID and phone number. Now you will see that according to your definition, key and primary key both sound similar. So what is the basic difference between keys and primary key? So a primary key is always unique plus not null. So what does this not null means? So not null means that particular column or that particular attribute cannot have null values. So it cannot accommodate null values. So here if we see ID cannot be null for any person, because ID is something which is generated whenever the person is onboarded into the company. So ID can never be null and ID will always be unique for a person. So we can say ID is a primary key. But coming to phone number. So phone number would be there for each and every person, but there could be a possibility that a person doesn't have any phone number, or there could be a possibility that the person's phone number is not updated in the database, but still the person is onboarded. So phone number is not something which would be always not null. It can have null values at the very start of the onboarding. Maybe the values are updated after the onboarding, but it can have null values. So as of now, ID is something which is unique as well as not null. So it is unique for each and every employee and it can't accommodate null values. So that is why it is called as primary key. It ensures that each row can be uniquely identified and accessed within the table. Now what is foreign key? A foreign key is a field in a table that refers to the primary key of another table. It establishes a relationship between the tables. So as of now we are dealing with the relational databases. So what is database? Database is basically collection of data. In relational databases we deal with the interrelated data. Now in database there could be many tables. So there could be table 1, table 2, table 3, but as of now we are dealing with the relational databases. So all these tables should have a link or should have a relationship between them. So to establish this link, foreign key help us, because in this particular table and in this particular table we establish a link using the foreign key. So foreign key help us to establish the link between the two tables. So let us see about primary key and foreign key in more depth. So primary key. A primary key is a key which uniquely identifies record in a table. As I told earlier, it ensures that each tuple or record can be uniquely identified within the table. So there is an ID which is serving as a primary key which uniquely identify each records or tuples in the table. So it is always unique plus not null. So as I told earlier that primary key is something which would be always unique and not null. It can't have duplicate values. It can't have null values. So ID would be always unique for each and every employee who has onboarded in our company, and ID won't be null because if any employee is getting onboarded in our company, the ID would be generated for that particular employee. So this is primary key. So the second key is the foreign key. So a foreign key is a field in a table that refers to the primary key in another table. So basically a key or a field which refers to the primary key in another table is called as foreign key. So consider an example. There are two tables, student and subject. This is having all the details about student. This is having all the details about the subject opted by the student. So it is having roll number, name and hometown, and it is also having roll number, name and subject. Now this particular table is having roll number as the primary key. And this is the student table. So the student table wants to have a relationship with the subject table because the subject table tells that what subject a particular student has opted. So we want a relationship between the subject and the student table. So what we do is to establish the relationship, the foreign key basically refers to the primary key in another table. So in this particular table, the primary key is roll number. So let's see that is there any attribute which is kind of referencing to this particular table. So that will act as a foreign key. So here you can see there is a roll number which is kind of referencing to the same roll number which is present in the student table. So this will be acting as a foreign key which will be referencing or which would be taking values from the student roll number. So in this way we can establish a relationship between two tables. So this roll number is called as foreign key and this roll number is called as primary key. This is called as foreign key because this is referencing to the primary key of another table. So a relationship between two tables are established on the basis of the foreign key. Now there are two things here. You can see base or reference table and referencing table. So let's understand what is this base table and what is this referencing table. So reference table is a table which is having a primary key. So whenever there is a table which is having a primary key, that is called as reference table or base, because this is the table which is referenced by another table which is having foreign key. So that is why this is called as referenced or the base table. Second table is the referencing table. So this is called as referencing table because this is having a foreign key and it references to another table. So a table which is having primary key is called as reference table. A table which is having a foreign key is called as referencing table. So the very first question which would be coming to your mind would be why we are reading about constraints, data types and keys at the first place. So do you remember I told you a query for creating a table in the very start of the videos, that was create table followed by the table name, and then we used to provide the column name, then the data type of the column and then the constraint of the column. So as of now you would know that why we need to provide the data type, so that any inconsistent or irrelevant data is not fed into our system. Now the second one was the constraint, which was kind of optional. You can provide constraints to a column and you can't provide constraint to a column. It totally depends on your use case. So constraints basically define the rules or the condition that must be satisfied by the data in the table. So consider that when you are creating a table, so at that particular time you are giving a column name, you are providing the data type and you are providing a constraint, consider primary key. So this particular column would be a primary key or this particular column would have not null values. So we are giving this constraint. So whenever we would be inserting data, if we insert data which doesn't follow this rule or condition, would be discarded and we would be seeing an error that this particular data can't be inserted because right now it is violating the constraint which we have given. So basically whenever we are giving a rule or a condition to that particular column or that particular attribute in a table, we call it as constraint. So common constraint include uniqueness of the data, nullability check and the default value, etc. Now here are some constraints which is present. So the very first constraint is the unique constraint. So unique constraint basically ensures that a value in a column are unique across the table. So basically whenever we are providing this unique constraint to any of the column in the table, it ensures that that particular column would only hold unique values. It can't hold any value which is duplicated, or duplicate values can't be stored in that particular column. So let's see from the MySQL workbench. There we would be creating a database and then we would be creating multiple tables in which we would be seeing about each and every constraint. So this is my MySQL workbench. Let us first create a database. So we would be creating a database for college. So we would just give this command create database college and we would just execute it. So we have executed, it has run successfully. Let's just refresh it here. And here we can see a college database which is created. As of now there are no tables. We would be making new tables for every constraint. So let's just tell the server that right now I am using this particular database to make the tables. So I'll just give use followed by the database name and then I'll execute this query. So this is also successful. Now all the tables which would be created inside this college database. Now let's first see the unique constraint example. So we would be right now seeing the unique constraint example. So we'll just comment this out and let's create a table. So we'll create a table student in which we would be giving columns. So while creating the tables, always make sure that the table name is always in small letters. It can't be in capital letters. It will throw an error. So we are creating a table student. In this particular table, we are giving some columns. So as of now, we are giving phone number and we would provide a data type for this and we will provide the constraint that is unique. So we'll just execute this query and here you can see a success. So once I'll refresh it, I can see a table with the name student is created which is having a column phone number. Now since I have given this unique constraint to this phone number column, so it shouldn't hold any duplicate values. So let's just insert some values into this table and check if the unique constraint is working or not. So we'll just do insert into, and then we'll give the table name, that is student, followed by the column name, that would be phone number. So I'll just copy this, I'll paste it here, and then we would be inserting the values. So let's just insert some values. So let's insert the first value as 1, 2, 3. Let's insert the second value as 4, 5, 6. And let's insert the third value again as 1, 2, 3 to check that if the unique constraint is working or not. So let me just execute this query. So here you can see that we are getting an error that duplicate entry 1, 2, 3 for the key student phone number. So we are giving the duplicate entry, and since we have given that it will be only holding unique values, this particular statement can't be executed. So what I'll do, I'll just remove this duplicate value and then I'll try running this query. So I've removed the duplicate values, all the values are unique. Let's just run this query again. So once I run the query after removing the duplicate values, you can see that I'm getting a success. So basically unique is somehow making sure that my particular table doesn't have any duplicated values. Now let's see for the next constraint, that is the not null constraint. So not null constraint basically ensures a column cannot have null value. So basically not null constraint makes sure that if a column is provided, it shouldn't have or it shouldn't store any of the null values. So let's see about this also in the MySQL workbench. So let's see for the not null constraint. So we'll just mention not null constraint and we'll just comment this out. And we'll just create a new table. So let's create a table student1 and let's just give some columns for the student1. So let's give the first column as age, which would be holding integer values, and as of now we are not giving any constraint to the age. Let's give another as roll number and it would be also storing integer values, and let's just put the not null constraint here. So let's just execute this query. And you can see a success. Let me just refresh it here. So here you can see a new table with the name student1 is created. Now let's just insert some values into the table. So we'll just do insert into student1. And here I'll only give one column name so that in the next column null value is automatically inserted. So I'll just give here age. And I'll just give the values. And here I'll give the value as 27. And I'll just execute this query. So what I have done is, right now I am only inserting values into the age. I am not inserting any value into the roll number. So let me just execute this query. So here you can see I'm getting an error. Field roll number does not have a default value. So it says that right now field roll number doesn't have any default value. So it is getting a null value. And as of now you have told that roll number can't have null values. So this query can't be executed. But when I make this age, comma roll number, and when I insert some value for the roll number as well, consider 1. And when I run this query, it would be successfully run, because right now I am giving a value to that roll number column, so it is not getting any null values. So this is how we can ensure the not null constraint. Let's see about the other constraints as well. So the third constraint in the list is the check constraint. So check constraint basically enforces a condition to be true for each row. So basically check constraint is kind of like you are making a check that if you are inserting any values into this particular column, there is a check which should be true. So consider that if you are inserting age of a person in a particular table, so you have to only insert the age of a person if he or she is greater than 18, so that you can make a voter ID for that particular person. So let's see from the MySQL workbench. So this would be for the check constraint. I'll just comment it out. So let's again create a new table. Create table student3 and we'll just provide the columns. So we'll just give age, which will have integer values, and we'll just give a check constraint. If check age is greater than 18, only then insert the values, otherwise don't insert the value. So we'll just execute this particular query. So query is executed. Here if you do a refresh, you can see a student3 is also created. Now in this student3 table, we will insert the values. So insert into student3 and here we will give the column name, that is age. And now we will insert the values. So let's insert. So here I have given the constraint that the age should always be greater than 18. Let's give an age which is less than 18. Let's give the age as 13. And let's just execute this query to see that if the constraint is working or not. So I'm executing the query. So here you can see that we are getting an error that the check constraint is present on this student3 age column. So we can't insert the value which is less than 18. And let's run the same query after giving the age which is greater than 18, 21. Let's just run this query. So you can see a success that this particular age is already inserted because this is greater than 18. So this is how the check constraint works. Let's see for the next constraint. So the next constraint here is the default constraint. So default constraint basically provides a default value for a column if no value is specified. So basically you remember that in the last example when we were inserting the data into the columns, if we are not providing any column name, null is automatically being inserted in that particular column. So if we want to avoid that null, if we want a default value which should be there, consider that you are a student and you are studying at a school. If you forget to provide that school name in your database, that would automatically take the school name. So let's just see about the default constraint as well. So default constraint basically means if no value is provided, the default value will be automatically inserted. So let's see for the default constraint. So we'll just create a table. So create table student 5, and here we would be giving the column names. So let's just give the first column name as school name, and it will take varchar values because it is a character string. So it will just take 50 characters, and here I'll provide this default constraint. So default would be XYZ. Like as of now I'm taking the school name as XYZ, and then I'll be providing next column as age, which would be taking integer values. So let's just execute this query. So you can see that we are getting a success. Now let's just insert some values into this table. So insert into student 5, and then we will provide the column. So as of now I'm not providing the school name because it will by default take the default value. So I'm just giving for age. So I'll just give age, and in the values I'll just give 19 for now. We'll just execute this query. So you can see that I'm getting a success on executing this query. So let me just see if the table is taking the default value or not. So I'll just do select star from student 5. So it will show all the data which is present in student 5, and I'll just execute this query. So here you can see that the school name XYZ is already taken by default. So I haven't entered any of the school name. It has taken the school name by default. So this is how the default constraint works. So if we give the default constraint, it will take the default value if none of the value is specified. If you specify any value, it will take that value. But if you don't specify any value, it will take the default value. So the next constraint is the primary key constraint. Now primary key constraint basically enforces the uniqueness of values in one or more columns. So a primary key basically enforces the uniqueness that two tuples can be identified uniquely whenever there is a primary key present. So primary key is always unique as well as not null. Both the unique and the not null constraint together is applied in the primary key. So when you are providing any column as primary key, it is by default unique, it is by default not null. So let's see about the primary key. So this would be primary key constraint. So we will see for two things. First is the uniqueness and second is the not null. So first we will create a table again. So we will create table and we'll give the name as student 6. Don't get confused at why I am creating so many tables. It's just for you to have a proper understanding about each and every constraint in depth. So that is why I am creating multiple tables. We can do this in the same table as well, but again that could be a bit confusing. So let's just give some columns. So we'll give age int, and then we will give roll number int, and let's just give roll number as primary key, and let's just execute this query. So you can see we are getting a success for this query. Now let's just insert the values. So first we will see if it is holding the uniqueness or not, and second we will see that all the values are not null. So let's see for the uniqueness first. So we'll just insert into, again we'll give the table name, that is student 6, and then we will provide the column. So the first column is age and the second column is roll number, and then we will give the values. So let's give the first value as, let's give the age as 12 and roll number as 1, and then we will give another age as 13, roll number as 2, and here we have to check that if it is following this unique thing or not. So let's just give a duplicate value. So we will give age as 14 for a student and again the roll number as 2. And let's just execute this query to see if it is taking care of the uniqueness or not. So here you can see we are getting an error because we have told that once a column is declared as primary key, it will always hold a unique and the not null value. And for not null also, let's execute the same query and do some changes. So we have to make this roll number always not null. So let's just not give any roll number here, and let's just insert only one value in age. So let me just execute this query. So here you can see we are again getting an error because for now roll number is having a null value and roll number is asking for a default value because primary key can never be null. Now the last constraint is the foreign key constraint. So foreign key constraint basically enforces a link between two tables by referencing a column in one table, that is primary key in another table. So in foreign key what happens is the foreign key is basically helping us to establish a link between two tables. So foreign key links two tables to have a relationship between them. So there are two tables, table 1 and table 2. Table 1 is having details about the student and table 2 is having the details about the course or the subject. Now table 1 is having ID, which is serving as a primary key as of now. So if we want to establish a relationship between the student and the course table, what we will do is we will search for this primary key if it's present here or not, the attribute which is like kind of referencing here. So we'll search for the same attribute here. So we can see that there is the same attribute which is present in the course table as well. So it will act as a foreign key and it will reference to the primary key of the student table. So in this way our relationship is established. Please take care this thing in mind, that one table would be having only one primary key but can have multiple foreign keys. So let's just see about the foreign key constraint. So we'll see foreign key constraint. Now for the foreign key, let's create a table first. So create a table with the name course that would be having some course details such as course name, and we'll give it as varchar 50. And then we want to establish this course table with the student table. Now this student 6 table is having age and roll number. So let me just provide a roll number here. So it would be roll number and that would be taking integer value. Now at the very last, I'll just establish a relationship between this roll number and the roll number which is present in the student 6 table. So what I'll do, I'll just provide foreign key roll number. I'll just mention it inside the brackets. Foreign key roll number references. I'll give the table name of which we are taking a reference, that is student 6, and then I'll provide the column name, that is roll number. And okay, so I've provided the foreign key and I've provided that which particular column here would be acting as a foreign key, and then I've given this references. So there's a small typo and I'll just fix it. So let me just execute this query. So once I execute this query, I can see a success. So basically a table with the name course is created, which is having a relationship with the table student 6. The student 6 primary key, that is roll number, is acting as a foreign key here, and there is a link which is being created. So before starting with foreign key, let's just re-revise some older concepts. So in keys, we learnt about two types of key. The very first one was the primary key and the second one was the foreign key. Now what is primary key? Primary key is a key which uniquely identifies all the records, or we can say rows of a table. Now consider that there is an employee table. Now in this employee table, we have some attributes such as employee ID, employee name, employee salary, employee address. Now in this particular table, we are treating ID as the primary key. So we have fed the details of employee 1, then employee 2, employee 3, followed by all the employees which is present in the organization. Now if I want to identify employee 1 from rest of the employee, would this ID be helpful to me? So the answer is yes. The ID would be helpful for me to identify employee 1 among all the employees which are present, because primary key says that if we are declaring any of the key as primary key, it is always unique as well as not null. So what does this mean? Uniqueness here means that ID cannot have any duplicated values. So employee 1 and employee 2 both can't have the ID as 1. It is not allowed when we are declaring ID as the primary key. So ID cannot have duplicated values. The second one is not null. So ID cannot also hold any null values, because again, if I am holding ID as null here, so it won't help me to differentiate between all the employees, because for employee 2 the ID is null. So null values are not allowed and duplicated values are not allowed whenever we are assigning any attribute, or we can say set of attributes, as primary key. So primary key help us for unique identification of all the records which is present in a table. Now let's move to the foreign key. So what is foreign key? Foreign key is a key which help us to establish relationship between two tables. So whenever consider there is a database, and as of now I am taking school database as an example. So in the school database there would be multiple tables. First one would be the student table, second would be the course table, third would be the teacher table, and so on. Now the student table and course table have a relationship between them. So the course table basically says that which particular student has opted which particular course. So this course tables helps me to know that if a student has opted a course of, let's say, course code as 100. So what are the course details, like what is the course name, who is the course teacher, and much more thing. And then this teacher table also have a relationship between the course table. So basically the course table tells that this particular teacher is gonna teach that particular course. So somehow we can see that there are some relationship which is established between different tables which is present in our database. So foreign key help us to establish a relationship, or we can say link between two tables. So whenever we want to establish a relationship or link between two tables, we use the foreign key concept. Now let's see the example which is present here. So there are two tables, first one is student and second one is course. So what is the first thing we will do? We'll identify the primary key of both the tables. So here you can see that ID is something which is unique for each and every student. So here ID is acting as a primary key. Now coming to the course table, here you can see that course ID is unique for each and every course. So here we can make course ID as primary key. Okay, so here course ID is acting as a primary key, here ID is acting as a primary key. Now you can see that this particular ID tells about the student ID, that for Rahul the student ID is 1, for Raj the student ID is 2, and for Riti the student ID is 3. Now in this particular table, if I add one more column which is of ID, like which is, you can say, roll number, like consider this as roll number, student roll number. So if I add a same column here, student roll number, so I can know that okay, a student with roll number 1 is having a course ID 100, is opted Hindi as a language or as a subject, and the teacher who is teaching is Ram. So basically this particular ID column is helping me to establish a relationship between these two tables, because from here I can see that okay, the ID is 1. So here if I come, the ID is 1, the name is Rahul. So ID 1, name Rahul, has opted Hindi as a course or as a subject, and the teacher who is teaching is Ram. So a relationship between these two tables are established. So this is called as foreign key. So foreign key is a key which references to the reference table and act as a primary key in the reference table. So whenever there is a foreign key which is present in another table, it is kind of acting as a primary key in the table to which it is referencing or to which it is establishing a relationship. So as of now, course table is establishing a relationship with student. So there is a key which is present which is kind of primary key in another table. So this key is acting as a foreign key, because this key is helping me to map all the details which is present in the course table to the student table. So there is a relationship which is established between table T1 and T2, which is student and course. So whenever a table which is referencing to another table, that is called as referencing or child table. So whenever we are having a foreign key in a table, that table we can call it as a referencing table or child table. Now what is this child table? So you might have heard this parent-child inheritance. That child always have some properties of parents, or child inherits some properties of parents. In the same way here, child table inherits some properties of the parent table. And whenever there is a foreign key which is present in child table, it is referencing to one of the table, that is called as reference table. So whenever a table is being referenced, it is called as reference table, or we can also say that it is called as base table, or we can say that it is called as parent table. So we can name it as base, referenced, or parent table, and the table which is having foreign key and which is referencing to other table is called as referencing or child table. Now foreign key help us to perform operations related to the parent table, such as joining tables or ensuring referential integrity. Now what is this referential integrity? Consider that there are two tables and they have a foreign key relationship between them, or they have established a relationship between them. This is also having a column as ID, and here also we are having column as ID, which is acting as a foreign key here and which is acting as a primary key here. Consider that in this ID, if I update ID from 1 to 2, so this particular 2 should be updated here as well to maintain the data consistency, because consider that someone makes a query here and someone uses the same query for here, that give me all the details of a person whose ID is 1, or give me all the course details of person whose ID is 1. So here 1 is not existing. So here it will say that okay, you are making a wrong query because 1 is not existing, but here it will give the detail. So basically data is kind of inconsistent. So we need to maintain the data consistency, that if anything is updated here or considered deleted here, that should be done same in the another table, or we can say the child table. So if any of the update or delete happens in the base table, that needs to be done in the child table. So that is called as referential integrity, basically maintaining the integrity of data in the tables which is having a relationship between them. Now the query to any column or attribute as foreign key. So we give create table and then we give the table name. So consider that there are two tables. The first table we are calling as base table and the second table we are calling as child table. Now this table is already existing and this table we are making it new. Now this particular table has base ID, consider name and other parameters, and here base ID is acting as a primary key. This particular child table is having its course ID and now it's having a base ID which is acting as a primary key in another table. So this is a foreign key which is referencing to the primary key of another table. So we'll give create table followed by the child table name. Then we will give all the attributes which are present here. So child ID, then we will provide the data type, that this attributes would be taking only these values. So we will provide int, and here CID is acting as a primary key. So we will provide this primary key constraint as well. Then we will provide the base ID and then all the values which is being accepted by the base ID, that is integer. Then we will give this foreign key like we will tell the database that this particular column is going to be my foreign key. So I'll provide this foreign key name, and then I'll provide that which column in the child table we want to be a foreign key, that is base ID. So I'll provide the base ID, and then here I'll provide references. I've made the base ID as foreign key, but I have to tell the database key, okay, this particular ID is being referenced as foreign key, but which table it's referencing to. So I'll give this references, and then I'll give the table name, that is base table name, and then which column this foreign key is referencing to, that is base ID. So in this way, while creating a table, we can declare the foreign key. So let's see from the MySQL workbench. So here I am creating a database of school. So I'll just execute the command. So I've created a database of school. I'll just do a refresh all. So here a database of school is created. Now I'll create a table student which will be acting as a base table as of now. So I'll just run the command. Okay, so we are getting an error, no database selected. So why we are getting this error? We have created the database school, but I haven't told the server that if I want to create the table, in which particular database I want to create the table. So no database has been selected. So we need to execute this use command. So this will tell the server, okay, now all the operations which are gonna happen will happen in the school database. Now you can see we have got a success. Now again we will run this create table student, and here you can see we have got a success. So once I do a refresh all, here in the tables, I can see a table with the name student is created, which is having columns as ID and name. ID is acting as a primary key and name is another column. Now I am creating a table course, which is a child table, which will be having foreign key, which will be referencing to the primary key of the student table. So what I'll do, I'll just give course, and then I'll give course ID, integer, and here in this particular table, course ID is acting as a primary key. So I'll give primary key, and then I'll provide the ID, which is coming from this particular student, and it is taking integer values, and then in the last line I'll provide that ID is a foreign key. So I'll provide ID here, and then I'll provide that which table it's referencing to. So references, and then I'll provide which table it's referencing to. So it's student, so I'll provide student, and then I'll provide the column or the attribute which it's referencing, so that is ID, and then I'll just execute this particular query. So you can say I've got a success, and here I'll do a refresh all. So here you can see that two tables are created. First one is student and second one is course. So course is having ID as a foreign key, which is existing in the student table, which is acting as a primary key there. So now let's see about cascading in foreign key. So just now I explained about referential integrity, that if there is any update which is happening in the base table, same should be happening in the child table, or if there is any delete which is happening in the base table, same should happen in the child table as well. So cascading are a set of rules which dictate what action should be taken automatically when a referenced row in the parent table is modified or deleted. So whenever there are two tables, first one is the parent table, second is the child table. So whenever there is any kind of insertion or deletion which is happening in the parent table, same should happen in the child table as well, as they are having a relationship via foreign key. So there are ways in which we can achieve the same to maintain the referential integrity. So there are three ways to maintain the referential integrity. First one is cascade. So if a row in parent table is updated or deleted, all the related rows in the child table will be automatically updated or deleted. So cascade says that if I give cascade command, what it will do, that if any of the attribute here or any of the value here is updated or deleted, same will happen in the child table. The second one is set null. So if a row in the parent table is updated or deleted, all the corresponding foreign key values in the child table will be set to null. So consider that in the ID, I have updated the value from 1 to 1a. So the same shouldn't be replicated here. Either what it will do, that ID is updated from 1 to 1a, so it will set a null value there, saying that this particular value is now being updated, and now for now we have set the value as null here. So foreign key values in the child table will be set to null. Now the third one is restrict or no action. So what it does, it blocks the modification or deletion of a reference row in the parent table if related row exists in the child table, thus maintaining the referential integrity. So if I provide this command at the last of creation of table, what it will do, consider that there is a ID which is here, and the same ID is present here, which is acting as a foreign key. So what it will do, that it will not allow any kind of updation or deletion happening in this particular ID table, because it will somehow affect the ID which is present in this particular table, that is the child table, and it is acting as a foreign key. So it will basically block the modification or deletion of the reference row in the parent table. So it will just block the modification of the ID which is present in the reference table. Now how we can achieve the cascading in foreign key? So these cascading action helps to maintain the integrity of data across related tables in the database. Now there are two ways in which we can achieve this cascading. First one is on delete cascade, and second one is on update cascade. So what does this on delete cascade does? So the on delete cascade clause indicates that if a row in a parent table is deleted, all the corresponding rows in the child table will be automatically deleted as well. So it says that if I am writing the query in which I am referencing attribute as foreign key, if at the very last I mention this on delete cascade, it will make sure that any of the data which is deleted in parent table will be deleted in the child table as well. What is on update cascade? So the on update cascade clause indicates that if a row in the parent table is updated, all the corresponding rows in the child table will be automatically updated. So it says that if there is any kind of changes or any kind of updation which has happened in the parent table, the same would be reflected in the child table. So while creating a table, at the very last we can provide this on update cascade, which makes sure that if any of the value which is updated in the parent table, that is the base table, the same should be replicated in the child table as well, thus maintaining the referential integrity. So before starting with the update command, let's just realize or understand what is the importance of update command, or how is this update command even coming into the picture. So what is SQL? SQL is basically a programming language which helps us to perform any CRUD operations on a data. Now what are these CRUD operations? So CRUD stands for create, read, update and delete. Now, whenever we want to perform such operations on our data, we use SQL. And there are some special commands in SQL which help us to perform all these operations. So, for the create, we have a create command in SQL, which help us to create any database, any table. For the read, we have a select command, which help us to show the data or the data which is present to make a query in the data. Then update, we have the update command in SQL. And then for delete, we have a delete command in SQL. So using all these commands, we can do manipulations in the data, basically perform the CRUD operations. Now in this particular video, we would be touch basing more on the update command. So before starting with the update command, let's just create a sample database. In that sample database, let's just create a table and fill in some details into the table. Then we would be updating some values, or we can say a record in a table, and see that if the values are being updated or not. So before making any of the database or any of the table, there are some requirements or some steps we should be following. So the very first step is make a database for a company XYZ. So we have given a requirement that we have to make a database for a company named XYZ. So what we will do, we will first run this particular query where we give create followed by the database, and then we provide the database name, that is XYZ. So this is the very first step we perform. Now here it will create me a database with the name XYZ in our server. So in the server, there could be multiple databases. For now, it is creating a XYZ database. Now the second command is use XYZ. So as I told that in a server, there could be multiple databases. Now I want to execute some queries. So how would the server know that if it's being executed in this particular database or this particular database? So we give this command use XYZ, which helps the server to know that if any operation or any queries are being performed, it would be performed in this XYZ database. So we will be hitting this particular query. Then the second requirement is, now in that particular database, we would be creating an employee table. So to create an employee table, we would be executing this query. We'll give create table followed by the table name, that is employee, and then we will provide all the columns which we need in this particular table. Basically you can say as schema of the table or the characteristics or attributes of this particular table. So we will give the column name followed by the data type, basically what all values the column will be holding. So ID can either hold string values, integer values, boolean values, any values. So we will be telling that ID would only be holding integer values. So whenever a person wants to insert a string value or a boolean value, it will throw an error, because we have told that ID would only be storing int values. And then we give a constraint. So what is constraint? Constraint is basically a set of rules we provide to particular column. So we are providing a constraint primary key, which says that this particular ID field will always have unique as well as not null values. So it means that ID can't hold duplicate values, ID also can't hold null values. And in the same way, we will give column name followed by the data type. The constraint is kind of optional. So we will again give the column name followed by the data type, column name, data type, column name, data type, and column name, data type. In this way, we can create an employee table in the XYZ database. Now the third requirement comes in where we have to fill the details into the table, basically insert some data into the table. So for that, we will execute this query where we will give insert into followed by the table name, that is employee, and then we will provide the order in which we want to insert all the values. So basically it gives the order, like firstly the value would be inserted into ID, second value would be inserted into name, third value would be inserted into age, fourth into department, fifth into city, and sixth into salary. So whenever here we give the values, we can provide multiple values followed by a comma. Like if I want to enter details of multiple employees, so I can enter the details of employee 1, then I can give a comma, and then I can enter details of employee 2, employee 3, employee 4, employee 5. Now in the values, the 1 is basically stored in the ID, as this is the manner in which we are inserting the data. Rahul is stored in name, 25 is stored in age, IT is stored in department, Mumbai is stored in city, and 1500 is stored in salary for the very first record, we can say, or the employee 1 record. Now in the employee 2, the same thing happens, employee 3, employee 4, employee 5. So here we have feeded among 5 details of each and every employee, including their ID, name, age, department, city, and salary. So we have created a database, we have used that database, we have created a table, we have inserted some values into the table. Now we want to see if all the values are inserted into the table or not. So the very fourth requirement is see all the data in the table. So let's see from the MySQL workbench, let's execute all these queries and create a database with a table employee so that we can perform any operations on that particular table. So I'll go to MySQL workbench. So here you can see that I have already written all the queries just to save time, but I'll be executing the queries one by one and would be explaining that how these queries are even working. So the very first thing was to make a database with a company XYZ. So I'll give the command create database followed by XYZ, and then I'll just run this. So here you can see that I've got a success, but in the schemas tab you won't be able to see anything. So you have to just right click and do a refresh all. So once you do a refresh all, you can see a database with the name or a schema with the name XYZ is created. When you open it, you would be seeing that there are no tables, no views, nothing here, because we have only created a database as of now. We haven't done any operation. Now the second operation is use XYZ. Again, we use this use XYZ or use followed by the database name to tell the server that if there are two schemas, SYS or XYZ, we want to execute all the operation on this XYZ schema. Now the second one was to make an employee table in the XYZ database. So we will just hit this create table, then we give this table name, and then we provide all the columns which we need in this particular table. We'll just run this query, and here you can see we have got a success. But here you won't be able to see anything. So you have to just again go and refresh all. So here you can see in the tables, our employee table is created, which is having all the columns as ID, name, age, department, city, and salary. Now we have to fill some details into the table. So I'll be just executing this query, which inserts data into the table followed by the given order, and then the values which we need to insert into the table. So I'll just run this. And here if I do refresh all, I won't be able to see the data which is present here. So to see the data, that if the data I've provided or if the data I've inserted is inserted correctly or not, or if the data is present or not, I'll just hit this particular query, which is select star from employee. Now this particular query, select star from employee, help us to see all the data which is present into this employee table. Basically the asterisk here means all. So select all from employee. So select all the data which is present in the employee table. So we'll just hit this query. About the select, we will be looking more on to the next set of videos, but for now you can understand that here we are trying to see all the data which is present into the table. So here you can see ID, name, age, department, city, salary, and all the data which we have fed is present here. Now let's go to the update command. So the update command in SQL is used to modify existing records in a table. Now consider that my name is Riti. I ordered something from Swiggy. I gave my name there. But my mistake, I wrote it as REETI rather than RITI. Now my name is displaying as REETI, but my name is RITI. So I raise a complaint to their customer care and I tell to correct my name. So they will ask me that what is the corrected name. So I'll provide my corrected name and I'll provide the name which is right now present. So basically I am somehow updating the value here of name from Riti, REETI to RITI. So basically update means whenever we are modifying any existing data which is present inside the database. Consider you have provided your age. By mistakenly someone feed it incorrect age. So you can ask that particular person to go ahead and update your correct age in the database. So basically update help us to modify any records or any values which is present into our table. So the query for update is this update, then we give the table name and then we provide here set. Basically means ki you have to update this particular table and you have to set the column name to this particular value. So basically if I am updating my name here, what I'll do, I'll update, I'll give the table name, I'll set, and then I'll provide the column name as name. I'll provide the value which is need to be set. So the value which needs to be set. If there are more values which are incorrect, we can provide it using comma separated way. And then I'll give the condition. Okay, I've given the name is equal to Riti. You have to set in this particular table, but where I have to set this particular name? So I'll provide the condition where name is equal to REETI. So I'm telling my database that go ahead and update the table with the table name this set name equal to Riti, like the updated value, and if there are more values I can give, and I'll tell my database ki you have to update the name as Riti, where right now the name is equal to REETI. So in this manner the update query mostly works. Now let's see some examples of this update query, some practice question, and then we will go ahead in the MySQL workbench and execute these queries. So the very first practice question is write a query to update the salary for all employees in the HR department to 50,000. So basically for HR department now there has been an increment which is applied to all the people who are working into the HR department. So rather than going ahead ahead and manually correcting all the salary, it's better to go ahead and execute a query which will update all the salaries of the people who are present in HR department to 50,000. So what the query would be, I'll give update, then the table name which we created employee, and then we will give the set salary equal to 50,000. So this is the updated value which I want to set. So I'll set the salary equal to 50,000, and then I'll provide the condition or the clause where department equals to HR. So go ahead, update the employee table where department is equal to HR and set the salary as 50,000. So let's just go ahead and execute this particular query into our MySQL workbench. So let's just execute that particular query. So what we will do, we'll give update, and then we will give the table name, that is employee, and then we will provide set and the value which we need to update, salary, equal to 50,000, and then I'll provide the condition that where I need to update this. So where department equals to HR, and I'll just execute this particular query. So here you can see that while executing this query, I've got an error, unknown column salary in the field list. So basically it's a typo, and I'll just correct it, and I'll just execute it again. Again, I've got an error. So what this error says, you are using a safe update mode. So what is the safe update mode? So let's learn about this safe update mode. So what happens ki right now we are creating some databases, we are creating some tables, we are doing update into the table, we are deleting some tables, we are deleting some databases. But in a normal scenario, this doesn't happen. Or in a real world scenario, this doesn't happen. Because there are companies who are having huge databases, which are having databases of employees, workers, their salary details, their personal details, and much more things. So whenever we are performing any update or the delete command, that could be harmful because there might be some APIs which would be depending on the data which is present into the database. So whenever we are updating any values or whenever we are deleting any values, we have to make sure that we are turning off the safe mode, which means we are telling ki, okay, I know that I am updating the value, okay, I know I am deleting the value, please turn off the safe mode. So for that, we will just execute this query, that is set SQL safe updates equal to 0. So I'll go here. So I'll set SQL safe updates equal to 0. And whenever I want to revert this, I'll execute this query and I'll just provide here as 1. And I'll just execute this query. So this query is successful. Now let's just execute this query of update. And now it's successful. So now we want to see that if the update has happened successfully or not. So we will just see all the employee details. I'll just run this command. And here you can see the department is HR and the salary has been updated to 50,000. So earlier the salary for the HR department was 2,000. Now the salary has been updated to 50,000. So let's go to the second practice question. Write a query to update the name of an employee from RAAJ to RAJ. So basically an employee name, as I told that I have given my name as REETI, but my actual name is RITI. So I want to update that value. In the same manner, we have to update the name of an employee whose right now name is RAAJ to RAJ. So for that, what we will do, we will give that update followed by the table name, that is employee. Then I'll give the set, which basically sets the value or set the updated value. So I'll give name equal to Raj, which is the updated value. And now my database wants to know that where you want to set this updated value. So I'll provide the condition where name is RAAG. So in this manner, we can update the name from RAAG to RAG. So this is all about the update command in this particular video. We would be learning about the delete and the select command in the next set of videos. So the delete command in SQL is basically used to remove records from the table. So it's not like that it removes a value or it removes a data from the table. It entirely deletes the record which is present in the table. So records here basically means the rows of a table. So whenever we want to delete an entire row, we use this delete command. So the query for this is delete, then we give from, and then we provide the table name from which table we want to delete, and then we give the condition that what we need to delete. So consider that I want to delete all the records of a person whose name is Riti. So what I'll do, I'll just put this delete from table name, and then in the where I'll provide the condition where name is equal to Riti. So it will delete all the records of mine from the database. So let's just see from the practice question, and then we will go to MySQL workbench and execute the queries. So the very first practice question is write a query to delete all the records from the employee table where department is HR. So I want to delete all the records which is present into our table for the people who are from the HR department, because I'm making a separate database for IT department, separate database for HR department, separate database for consulting department, and much more things. So what I'll do, I'll just give this query delete from, and then I'll give the table name which is employee. Then in the condition, I'll provide that from where I want to delete. So I want to delete the department equal to HR. Now what it will do, consider that this is my table. And this is the department and these are all the details. Consider the department here is IT, it is HR, it is again IT, and it is again HR. So it will find all the HR department which is present in my table, and it will delete just all the departments which is having the name as HR. So it will delete all the department which is having the name as HR. It's not like that it will only delete one row, it will delete all the rows with the name HR. So let's just go to MySQL Workbench and see how the delete works. So we'll give delete from, and then we will give the table name, that is employee, and then we will provide the condition where department equals to. So now here we have only one HR department. So let's use the IT department, because here we are having two IT departments. So we will be seeing that how it is deleting all the records which is present into our table with the department as IT. So I'll just give IT and I'll just execute this particular query. So this query is a success. Now let's just use this select star from employee to see all the records. And here you can see that we can't see any of the record with the name department name as IT. So now you can see that whenever we are deleting anything, and if we are providing the department as IT, it will search in the entire table with the departments and as ID, and it will delete all the records who are having the department name as IT. It's not that it's only deleting one record, it will delete all the records with the department name as IT. Now let's see the second practice question. So we have to write a query to delete the record of an employee having the name as Raj. So here we are deleting the record of an employee who is having the name as Raj. So what query we will write? We'll give delete from, and then we will give the table name, that is employee, and then here in the condition we will provide where name, and then we will provide the name as Raj. So let's just execute this query as well. So I'll just close this and I'll use delete from, and then I'll give the table name as employee, and I'll give where name equals to, and I'll give Raj, and I'll just, so the Raj name is RHA, and I'll just execute this. So you can see that I've got a success. Again, I'll just hit this particular query, and here you can see that I can't find any person with the name Raj. So whenever it will find any person with the name Raj, it will delete all the records which is present into that particular table with the name Raj. So in this way, delete command works. So whenever we want to retrieve data from our table, we use this select command. So select command is a DQL command, that is data query language command. It is basically used to retrieve data from the database. So whenever we want to get or we want to retrieve some data from the database, we use this select command. Now we can provide specific columns from which we want to retrieve data. Either we can retrieve all the data which is present into our table. So there are two queries which we can use. First one is select. Then we provide all the columns which we want to see or which data we want to see. So we will provide the column name, column 1 name, column 2 name, and then we will provide from, and then we will provide the table name, like the table name from which we want to retrieve the data. So it will retrieve the data present in a specific column in a table. Then there is another query which is select star from table name. So this star basically means all the columns which is present into our table. So this star basically means all. So whenever we want to see all the data which is present in our table, we use the select star and then we provide the table name. So it helps us to retrieve all the data which is present in our table. So let's just see the example of select. So consider the first example where I want to only see the name and age of an employee from the employee table. So I'll use select, and then I'll provide the column names from which I want to see the data. So first one is name, second one is age, and then I will provide the table name. So the table name is employee. And then I'll just execute this query. So this is a success query, and here you can see that I can only see the name and age. So this employee table is having more columns, but as of now I've told that I want to only retrieve the data from the name and age which is present in the employee table. So basically it helps us to retrieve data from some specific column. If you want to retrieve the data, like the entire data which is present in this particular table, so we give select star, which is basically pronounced as all, and then we give from, and then we provide the table name which is employee. And whenever we execute this, we can see the entire data which is present in all the columns. So basically you have seen that in the earlier videos also we were using this particular command select star from which was helping us to see all the details or all the data which is present into the table. So select command help us to retrieve all the data or some of the data which is present into the table. So let's understand about where clause, its importance, how it helps us to filter data, and much more things. So without any further ado, let's get started. So whenever we want to filter the data, we use this where clause. Now where clause helps us to filter the rows based on a specified condition. Now what does this mean? So consider that I want a detail of a person whose age is 25, or I want all the details of a student who are having marks greater than 90. So basically I'm giving a condition that the age should always be greater than or equal to 25, or the marks should always be greater than or equal to 90. So whenever I'm providing any kind of condition to filter some of the data, because consider that I'm saying that I want the details of a person. So it will send me all the details, or it will show me all the details of all the person who are present in that particular table. But when I put up some condition like age should be 25, now what it will do, it will go one by one and check all the records, and wherever it will find age equal to 25, it will return that particular result and show me that particular result. So I am somehow giving some condition to get some filtered set of data. So in that way, where clause helps us. You have seen in the earlier videos as well that I was using the where condition along with update, along with delete, sometimes along with select also we use the where condition. So where condition or where clause is oftenly used whenever we want to apply any condition to our data. So here is a query on how we can use the where clause. So consider that I am trying to fetch some of the columns from a given table with a particular condition. So what I'll do, I'll provide the select command, then I'll provide all the columns from which I'm fetching the data, then I'll provide from, I'll provide the table name from which I'm fetching the data, and then I'll provide the where, and then I'll provide the condition, that what is the condition on basis of which I want all these columns to be filtered. So here is an example. So here I am kind of fetching or filtering out all the data of an employee whose age is greater than 20. So what I'll do, I'll just do a select star, which will make sure that all the data is selected. So basically till here, I am having all the data which is present in my table from table employee. So this is the table employee. Now here, there is a condition where age is greater than 20. Consider there is a age column in this particular table employee. And in this age column, we have ages such as 18, 20, 25. So now what will happen here, whenever I'll give where age is greater than 20, it will go record by record and see, here is the age greater than 18? No. So discard this value, it won't be shown in the final result. Now here, is the age greater than 20? It is 20 but not greater than 20. So this will also be discarded. Here, is the age greater than 20? Yes. So it will be shown in the final result. So in this way, we use the where clause. Let's see from an example as well. So this is my MySQL workbench. I have already created a table employee and I have already feeded some data in that particular employee table. Now here I'll be using this where condition to filter out all the employees whose age is greater than 25. So what I'll do, I'll just give select star from, and then I'll give the table name, that is employee, and then I'll provide the condition where age is greater than 25. So firstly, I'll see that what all data is present in my current table. So I'll just hit the select star from employee. And after hitting, I can see that all the data which is present in my table. I have actually, after the next set of videos, I have feeded all the data again because we are seeing about the SQL queries and we need much more data to perform the queries. So now I'll just execute this query. And here you can see that there are only two people who are having age greater than 25, and I can see all the details of that particular person whose age is greater than 25. So basically where clause is helping me to get the filter data, like on the basis of condition, I can get a filter data which would be really helpful for me to execute some of the complex queries. So if you remember, in the very start of the lectures, we discussed about types of SQL commands. So there we learned about 5 types of SQL command. The very first one was DQL. The second one was DML. The third one was DDL. The fourth one was DCL, and the fifth one was TCL. Now what is DQL? So DQL basically stands for Data Query Language Command. So whenever we want to make any query into our data, or whenever we want to fetch the details from our database, we use this DQL command. Now the second one was DML command, that is Data Manipulation Language Command. Now Data Manipulation Language Command is basically used whenever we want to manipulate some data, like whenever we want to insert some data, whenever we want to update some data, whenever we want to delete some data, basically doing manipulations on the data. The third command was the DDL command, that is Data Definition Language Command. Now Data Definition Language Command mostly deals with the definition or the schema of the data, basically like creating the table, creating the database, doing some modification in the database, doing some modification in the table. So whenever we are dealing with the schema or the definition of the table, we use this DDL command. Now the fourth one is DCL command, that is basically Data Control Language Command. Now in this Data Control Language Command, we set some controls on our database. So in that case, DCL command is used. The fifth one is TCL command, that is basically Transaction Control Command. So whenever we are doing some transaction and we need some control on that transaction, we use this TCL command. Now in the DQL command, we have already learnt about the select command. In the DML command, we have already learnt about the insert, update and delete command. In the DDL command, we have already learnt about the create and drop command. So in this particular video, we would be learning about the alter command, and then we would be learning about the truncate and the rename command. Now what is alter command? So alter is a DDL command that is used to modify or change existing database objects such as table, indexes or constraints, basically doing some modification in the schema. So whenever we want to do any kind of modification into our database object, into our definition or into our schema, we use the alter command. So consider that right now I am having an employee table in my employee database. Now in this particular employee table, I am having 3 columns, but there comes a requirement where I need to add one more column to this employee database. So this particular addition of column is done using the alter command. Consider that there is one more requirement which comes that you have to change the column name from employee ID to ID. So this particular change is also done using the alter command. So whenever we want to do any kind of modification or changes in our database, tables, schemas, we use this alter command. So let's see all the things that alter command can help us do. So mostly it is used to modify the schema. So whenever we want to do some modification in the columns like addition of new column, deletion of column, modification of column and much more, we use the alter command. So let's see how the alter command is used, the queries, and then we will go to the MySQL workbench and execute all the queries. So the very first use case is adding a column. As I told that alter command basically help us in doing any modification in the schema. So what is the schema? So whenever we provide all the column names or the characteristics of our table, we call this as schema. So whenever we want to add a column, basically doing some modification in the schema, we use the alter command. So the query for adding a column is alter table, then we provide the table name, and then we provide this add, and then we provide the column name, which column we are adding, then the data type of that particular column, and if we have any constraint or not, we provide this. So whenever we used to create the table, we used to provide all these values like the column name, data type and constraint. In the same way, whenever we are adding a column, we provide all the properties like column name, data type and constraint, and we provide this alter command followed by the table, and then we provide the table name in which we want to alter the data. So let's see from the MySQL workbench how we can add a column in our particular table. So here you can see that we already have a database with the name XYZ, and in that particular XYZ we have a table called as employee. Now in this particular employee table, we would be adding one more field, that is employee date of birth, which is not existing as of now. So what we will do is, we will give this alter, and then we will give the table provided by the table name, that is employee. Now we'll add a column DOB, so we'll give add, and then we will give the column name, that is DOB, then we will give the data type, that is varchar, and let's give the character limit as 20. And then we will provide the constraint. So if we execute the query just now, what it will do, that it will create a DOB column name, but all the values at that DOB column name will be null. So if you want any default value to be there, you can give a default constraint. So we can give default, and here we can give the value as NP, that is not present. So if we run this particular query, what it will do, it will first go, it will alter the table employee, it will add a DOB column, and then it will give the default value as NP wherever null is present. So let's just execute this query. So once you execute this query, you can see a success, and when we will try to see all the details of this particular table, you can see that a DOB is created with NP because all the values for now is null. So it has taken the default value, that is NP. Now let's see the second use case of alter command, that is drop a column. So whenever we want to drop or delete a column, we use this alter command. So here you can see we have given the query as alter, and then we provide the table followed by the table name, and then we provide the drop command, then we give the column which we want to drop, and then we provide the column name. So let's go to MySQL workbench and let's just execute this query. So for now we have created this DOB column. Let's just delete only this particular column. So first I'll give alter, and then I'll provide table, and then I'll give the table name, that is employee, and then I will provide the drop command, and then I will provide column saying that I want to drop the column, and then I will provide the column name, that is DOB. Now let's just execute this query. So you can see the query is successful. Let's see that if it has been deleted from our particular table or not. So we will just execute this query, and here you can see that we can't see any DOB field. So this particular column DOB is deleted whenever we use this alter command followed by the drop command. Now the third use case is modify the data type of an existing column. So whenever we want to do some modification in the data type of an existing column which is present, we use this alter command. So for that we use this modify clause. So the modify clause is oftenly used with an alter table statement in SQL. It allows us to change the definition or the properties of an existing column in a table. So whenever we want to change the definition or the properties of a column in table, we use this alter command along with the modify clause. So here you can see the query. So the query is alter table, then we give the table name, like which table we want to do modification, and then we provide this modify command, and then we provide the column name, like in which column we want to modify, and then we provide the new data type, like which new data type we want to set for that particular column. So the our command modifies the column name to a new data type. So let's go to my MySQL workbench and let's see how it works. So for now, let's just modify the data type for age. Let's make age as varchar. So what we will do, we will give alter, and then we will provide table, and then we will provide the table name, that is employee, and then we will provide this modify, and then we will provide the column name, that is age, and then the new data type. So the new data type for age is varchar 3. So let's just execute this query. So you can see that we have got a success. So for now, the data type for this particular age column has been changed to varchar. Now the fourth use case is change the name of an existing column. So whenever we want to change the name of an existing column, like in earlier use case we saw that how we can change the data type of a column. In this use case we can know that how we can change the name of that particular column. So the change command is often used with an alter table statement in SQL. It helps us to change the name or data type of a column within a table. So whenever we want to change the name or change the data type of a column in a table, we use this change along with the alter command. So the query is alter table followed by the table name, and then we provide this change, then we provide the old column name, and then we provide the new column name, like from old column name to the new column name, like what is the new column name you want to give, and then if there is any new data type for that particular column, we provide in this way. So the above command changes the old column name to a new column name and also its data type. So the old column name is changed to new column name and the new column name has a new data type. If the new column name doesn't have a new data type, you can give the data type of that particular old column name only. So let's go to MySQL Workbench and see. So let's just modify this age column name to employee age. So let's see how we can do. So we'll give this command alter table followed by the table name, that is employee, and then we will provide this change, and then we will provide the old column name, that is age, and then we will provide the new column name, that is employee age, and if there is any new data type, else we need to provide the data type of this age column only. So that is varchar 3, and let's just execute this query. So once you execute this query, you can see a success. So let's see if we are able to see this in our table or not. So let's run this select star from employee. And here you can see that the age column name has now been modified to employee age, that is EMP age. So in this way, using the alter command, we can change the column name as well. So this was one of the way in which we can rename our column. There is one more way in which we can rename either our table, our column, our constraints and much more. That is using the rename command. So the rename command is used to change the name of an existing database object such as a table. So whenever we want to rename the table name, column, so whenever we want to rename the column name, index, or constraint whenever we want to rename the constraint name. So the query for the same is alter table, then the table name, and then we provide this rename, and then we provide like which thing we want to rename, like table, column, constraint, anything, and then we provide the old column name, like here we are renaming the column, so we will provide the old column name, and then we provide this 2, like basically you want to rename the old column name to the new column name, so we provide 2 and then we provide the new column name. The above command renames the old column name to the new column name. So let's see from the MySQL Workbench. So what we will do now, we will revert this employee age to age. So what we will do is we will give this alter table followed by the table name, that is employee, and then we provide the rename, and then we provide what we want to rename, that is our column, so we will provide column, and then we provide the old column name, so that is EMP age, and then we provide this 2, and then we provide the new column name, so we will give this age. So let's just execute this query. So you can see that we have got a success, and when we execute this command, select star from employee to see all the data present in our table. So you can see that now this EMP age has now been renamed to age. So in this way we can rename our column name, table name or constraints. So what is this rename command? Rename command is used to change the name of an existing database object such as a table, column, index or constraint. So whenever we want to do any kind of changes in any of the database object like table, column, index or constraint, we use this rename command. So as the name suggests, rename. So whenever we want to rename or whenever we want to give a new name to a table, a column or a constraint in SQL, we use this rename command. Rename command comes under the DDL command, that is data definition language command. So the data definition language command basically deals with the data definition, the data properties, or we can say the database schema. So whenever we are doing any changes in the database schema, database definition or database properties, so there are many use cases of the rename command like renaming a table, renaming a column or renaming a database. So let's see about all these one by one. So the very first query is table renaming. So whenever we want to rename a table, what is the query to do so? So first we will give this rename command and then we will provide what we want to rename. Basically we want to rename the table, so we will give table and then we will provide the old table name and then we will provide this to and then we will provide the new table name. Basically this query means ki rename the table from the old table name to the new table name. So the above command renames the old table name to the new table name. So let's see from the MySQL Workbench that how it is happening. So let's rename this employee table to the employees table. So what we will do is we will give this rename and then we will provide what we want to rename. So we will provide this table and then we will provide the old table name, that is employee, and then we will provide this to and then we will provide the new table name, that is employees. And we will just execute this query. So you can see that we are getting a success, but here we are still seeing this employee. So we just need to do a refresh all in the schema tab. So once you do a refresh all, you can see that in this particular XYZ database, we have a table with the name employees. So if you try to see all the details of the employee table, you won't be able to see, because right now we have renamed the employee table to the employees table. So whenever we want to see the detail of employee table, if you run this particular query, that is select star from employee, you will see a error, because right now the employee table is not existing in this XYZ database, because we have renamed the employee table to employees. And whenever you give the new name, that is employees, and if you run this query, here you can see that you can find all the details. So in this way we can rename any of the table. Now the second use case is when we want to rename a column. So to rename a column, since it comes under the schema, so what is schema? Schema is basically all the properties or the attributes or the characteristics of table which is displayed by the column. So whenever you want to do any kind of changes in the schema, we use this alter command. So we give this alter, and then we provide the table, and then we provide the table name in which we want to alter the data, and then we provide this rename command, then we provide what we want to rename, that is column, and then we provide this old column name, and then we provide this to, and then we provide this new column name. Like we want to go ahead, we want to alter some data in that particular employee table, and we want to rename a particular column to a new column name. So let's see from the MySQL workbench. So let's just rename this name column to employee name, that is EMP name. So we will give alter, and then we will provide table, and then we will provide the table name. So for now we have modified the table from employee to employees, so we will give employees, and then we will provide rename, and then we will provide what we are renaming, that is column, and then we will provide the old name, that is name, and then we will provide to, and then we will provide the new name of the column, that is EMP name. Just execute this query. And here you can see that now the name has been modified to EMP name, and here we are getting a success. So whenever you will try to fetch all the details or see all the details of the table, so here you can see now that name has been renamed to EMP name. So in this way we can rename any of the column in our particular table. Now the third use case is whenever we want to rename our database. So we give this rename, then we give database, and then we provide the old database name, then we provide this to, and then we provide this new database name. Now in this particular renaming of database, there are many security risks involved, because we can't go ahead and rename any of the database. So there are some security requests and protocols which needs to be accepted before renaming any of the database from the old database to the new database. So it mostly depends on the server to server that if the server allows renaming of database or not. So what is truncate command? This command is used to remove all the rows from the given table, leaving the table empty but preserving its structure. So it basically means that whenever we have a table and there are some data which is fed into our table A, B, C, D, E, F, G, H, I, and whenever we give this drop table name command, so drop table name command, what it does, it basically deletes the table from the database. Then we give this delete command. So delete command basically deletes the data on a given condition. Then this truncate command comes into picture. So what truncate command does, it truncate command clears all the data which is present in our table, but it preserves the structure of the table. Basically you can say that table is there, that is an empty table, all the data inside that particular table is cleared using this truncate command. So let's see from the MySQL workbench how this truncate table works. So here we already have a XYZ database. We will create one more table in this particular XYZ database. We will try to truncate or delete all the data which is present in our table, and then we will see that if our table is preserved or not, or if the structure of table is preserved or not. So we will just create a table with the name salary details. And in this particular table we will provide some columns. So let's provide the first column as salary int, and second we will provide increment, and let's just give this also int. So let's just execute this query. So once you execute this query, you can see a success, and when we will go here, we'll do a refresh all. Here you can see that two tables are created. First one is employee table, and the second one is the salary details, which is having salary and increment. Let's just feed some data into this particular table. So we will give insert into, and then we will provide the table name, that is salary details, and then we will provide the manner in which we want to feed the data. So first we will give salary, and second we will give the increment, and let's just provide the values, and here we will start giving the values. So let's just provide the first value as 1200, and the increment is 6%, and the next salary is 1500, and the increment is 4%. Let's just execute this query. So here you can see that we have got a success. So let's see if all those details are fed in our table or not. So we'll give select star, and then we will give from, and then we will provide the table name, that is salary details. And let's just execute this query. So here you can see that all the data which we gave is feeded here. So now let's see that how this truncate command is working. So what we will do, we will just truncate this particular table. So whenever we truncate this particular table, it says that all the data which is present inside the table would be deleted, but the structure will remain preserved. So we'll give truncate table, and then we will give the table name, that is salary details. And let's just execute this query. So here you can see that I've got a success. If I go here and I do a refresh all, I can still see the salary details table is here. It means the data is only deleted, the table is still there. So let's see if all the data is deleted or not. So here you can see that there is no data which is present in salary and increment. So in this way truncate table command works. It basically deletes all the data which is present in our table, but it preserves the structure, or it preserves the table. Only the data is deleted. So firstly, let's start with the truncate command. So truncate command is basically used to remove all the rows from a table. What does this mean? So consider that there is a table employee. And in this employee table, we have some rows, we have some columns. So what truncate command will do? Truncate command will clear all the rows or all the data which is present in our table, which will make the table empty but will preserve the structure of the table. So there would be a table, but that particular table would be empty. There would be no rows in that particular table. All the data would be deleted. So it basically removes all the rows from the table. The command for the truncate is truncate table, and then we provide the table name. Now the next is the delete command. So the delete command is basically used to remove some specific rows from a table based on a given condition. So whenever we want to delete a specific row on a given condition, like delete or remove all the rows where the age is greater than 20. So whenever we are providing some specific condition, it executes the delete operation and it deletes the entire row. So the command for the same is delete from table name, and then we provide where condition. So it basically deletes some rows on the basis of condition, but the truncate deletes the entire rows, like all the rows which are present in our table. The third one is drop command. So the drop command is used to completely remove the table. So it not only deletes the data, it also deletes the entire table. So it removes the existence of table. If in a database there is a table, and if we use the drop command for that particular table, that table would be deleted. There would be no existence of that particular table. So the command for the same is drop table, and then we give the table name. So if this is a table employee, in this particular table, if we are using the truncate command, it will go ahead and delete all the particular data which is present in this particular table, and it will delete all the rows which is there in the table, but it will preserve the structure of the table. Basically the schema of the table would be preserved. If we are using the delete command, it sees that if this particular rows specify the condition, if this particular row specify the condition, it deletes this particular row, but if this row doesn't specify the condition, it leaves this particular row, and if this specifies the condition, it deletes this row. So it deletes the rows based on a specified condition. The drop command entirely deletes the table. So it doesn't only deletes the data which is present in the table, it entirely deletes the table. So this was the basic difference between truncate, delete and drop command in SQL. So what does this distinct keyword means? Distinct basically means unique. So whenever we want any unique values, we use this distinct keyword. So distinct keyword is used with select statement to retrieve unique values from a column or a combination of columns. So whenever we want to retrieve some unique values from a given column or a combination of columns, we use this distinct keyword. Now let's see from an example. Consider that there is a table of employee which is having three columns. First one is ID, second one is name, and the third one is city. So let's just feed some data. So ID is 1, name is Ram, city is Pune, ID is 2, name is Ram, city is Mumbai, ID is 3, name is Radha, and the city is again Pune. So we have made a table, we have entered the detail of 3 employees, and now we want to see that how this distinct keyword is working. So consider that right now I want the distinct values from the city column. So what it will do, it will go to the city column, it will start fetching the values. So the very first value is Pune. Now it has nothing to compare with because it is the very first value. So it will print Pune in the output. Now Mumbai is not existing in row 1. So Mumbai is also a unique value because it is not existing in the upper values. So we will print Mumbai also in the output. Now coming to the third row, that is Pune. So Pune is already existing in row 1, not in row 2 but in row 1. So this value would be discarded. So we would be only seeing Pune and Mumbai in the output. So it gives us the distinct value for the city column. Now consider that we want a distinct value in a combination of columns. Consider that we want to see distinct values in name and city. So what it will do in the output, first for Ram and Pune there are no any values to compare. So it will give Ram and Pune in the output. Now coming to the second row, it will see that is there any combination of Ram and Mumbai together present in any of the above rows. So it can find a name as Ram, but the city is Pune. So there is no combination with the name Ram and Mumbai. So it will print Ram and Mumbai now. And now coming to the third column, so it will search for the name as Radha and city as Pune. So it will see in row 2 and row 1, is there any name of Radha existing along with the city Pune. So there is no combination of Radha and Pune, so it will print Radha and Pune as well. So in this way, we can either get the distinct values from the combination of column or from a single column. So to get the value from a single column, we use this query, that is select, and then we provide this distinct keyword. Then we provide from which column we want the distinct value, and then we give from, and then we provide from which table we want this distinct value. So select distinct, then the column, and from table name. When we want to have a combination of distinct values, so we give this select distinct, and then we provide all the columns from which we want the distinct value or the combination of columns, and then we provide from, and then from which table we want the distinct values. So let's see from the MySQL workbench that how this distinct keyword is working. So here, let's just create a database with the name company. Let's just create a table with the name employee, insert some details into that particular employee table, and let's just use this distinct keyword. So to save the time, I have already written the query. So we will just execute this create database followed by database name, which will create a database of company in my schemas tab. So here you can see a database with the name company is created. Now I will execute this use company, which will tell the server that all the operation now needs to be performed in this particular database. Now I will create a table employee in this particular company database. So here you can see a success. Once I do a refresh all here, I can see in table our employee table is already created. Now let's just fill some details into this employee table. So we will execute this insert into command, and here all the details have been fed. Now let's see that if all the details are fed correctly or not. So here you can see that ID, name, age, department, city, salary, all the details have been fed for 5 of the employees. Now let's use the distinct command. So I want to see the distinct value of department in this particular employee table. So I'll give the query as select distinct, then I will give the column name, that is department, and then I will give from, and then I will provide the table name, that is employee. So it will give me the distinct value of this particular department. So let me just execute this query. So once I execute this query, you can see that I am getting all the unique department names, that is IT, HR, marketing, and finance. So in this way, we can see the distinct value from this particular column, that is department. Let's see some distinct value from a combination of columns. So I want to see a distinct value, select distinct, and the column from which I want to see the distinct value together is age and department. So I'll give department, and then I'll give age, and then I will provide from, and then I'll give the table name, that is employee. So let's just execute this query. So once you execute this query, you can see that IT, HR, IT, marketing, and finance, and with the IT here is the age as 25, with the IT here the age is 27. So you can see that in the department we can see that IT is repeated twice, but when we see the combination of department and age, that is IT and 25, IT and 27, there are no any other combination existing with the same. So in this way we get the combination of distinct value for 2 columns. So what is operators in SQL? So whenever we want to perform any operations on the data, we use operators. So consider that there is a table. In that particular table, there are many sets of data. So whenever we want to perform any operation on that particular set of data, we use the operators. Now operators are of various types. Let's see about each and every types of operator. So the very first operator is arithmetic operator. Now in this arithmetic operator, we have addition, subtraction, multiplication, division, and modulus. Now let's see an example of arithmetic operator. Consider that my table is not updated from the last 1 year, and in this particular year there are some people who are about to retire. So I'm writing a query in which I am checking the people whose age plus 1 is equal to 60. So here I have written select star from employee where age plus 1 equals to 60. So it will give me all the details of a person whose age is equal to 60. So in this way we can use the arithmetic operator. We can also use the subtraction, we can also use the multiplication, we can also use the division. Now here comes the modulus. Now what is modulus? Modulus basically gives us the result of the remainder. So whenever we are dividing any two numbers, like whenever we are dividing 2 by 4, so we get remainder as 0. So this is the modulus. Now the second operator is the comparison operator. In the comparison operator we get this equal to, not equal to, greater than, less than, greater than or equal to, or less than and equal to. So let's see from an example. I want to see the details of all the employees whose age is greater than 20. So I'll use the select star from employee where age greater than 20. So here I have used the comparison operator, and here I am getting the details of all the person whose age is greater than 20. I can also use this age equal to 20 if I want the details of all the person whose age is equal to 20, or I can also use age greater than or equal to 20, which will also include the 20-year-old employee. Now the third operator is the logical operator. Now in the logical operator we have 3 operators. So the very first is AND, the second is OR, and the third is NOT. Now AND operator basically combines 2 conditions and return true if both of the conditions are true. So consider that we have given 2 conditions, that age is greater than 20 and city is equal to Pune. So it will give the output only when it finds the age which is greater than 20 and the city which is equal to Pune for a particular employee. So here you can see an example, select all from employee where city is equal to Pune and age is greater than 80. So consider that there is a table having age and city. Now in age we have some values as 18, 20, 25, 29, and in city we have Pune, Mumbai, Pune and Pune. So what it will do, it will match for both the conditions. So first it will see where the age is greater than 80 and city is Pune. So for the very first row, is the age greater than 18? No. So if one condition is discarded, it won't see for the other condition. Now for the second row, is age greater than 18? Yes. Is city equal to Pune? No. So this one is also discarded. Now for the third row, is age greater than 18? Yes. Is city equal to Pune? Yes. So it will show 25 Pune in output. Now for the fourth row, is age greater than 18? Yes. Is city equal to Pune? Yes. So it will show all the details of this particular employee as well. So it will show all the details of this employee and this employee. Now the second operator is OR operator. So it combined two conditions and return true if either is true. So if age is greater than 80 but city is not equal to Pune, it will return all the values. If city is equal to Pune and age is not greater than 80, it will also return that values. So consider in the same table. So for the very first row, is age greater than 18? No. Is city equal to Pune? Yes. So it will show the details of this particular employee. Now is age greater than 18? Yes. So it will not check for the second condition. So it will show the details of this particular employee. Now is age greater than 18? Yes. So it will show the details of this particular employee as well. Is age greater than 18? Yes. So it will not see for the third value because the first value is getting corrected. So age is greater than 18. The first condition is evaluating as true. So it doesn't need to see the second condition. Now for the not, it reverses the result of a condition. Return true if condition is false. So consider a condition where I want only the details of a person who are not in IT or HR department. The persons who are in other department, I want only the details of that particular person. So we can use the not operator there. So here you can see a query, select star, which means all, from, and then we provide the table name, that is employee, and then we provide it here where, and then we provide department, here we provide not, and here we provide a in operator about which we would be discussing in further slide, and here we have given all the department in which we don't want the particular employee to be. So if our employee is not in IT or HR department, give me all the details of that particular employee. So it will give me all the details of that particular employee whose department is not in IT or HR. Now what is this in operator? So in operator basically checks a value matches a list of value or not. So in this in operator we provide some list of values. This list of values can either be in this particular department column or cannot be in this particular department column. So basically it checks that if in this particular department column, if these values are existing or not. If these values are existing, return the record of that particular employee. If these values are not existing, then don't return the record of that particular employee. So it basically select star from employee where department in IT or HR. So it returns all the employees details whose department are in IT or HR. So let's see about all these operators from MySQL Workbench. So here we have a company database. In that company database we have an employee table. So let's see for the logical operators. So let's see for the AND operator. So for the AND operator we will give select star from, and then we provide the table name, that is employee, and we provide the condition where age is greater than 20 and department is equal to IT. So give me the details of all the employees whose age is also greater than 20 as well as the department is ID. So let's execute this query. So once we execute this query, we can see that we are getting the details of all the employees whose department is IT and the age is also greater than 20. So in this way, we can fetch all the details of a particular employee in which the age is greater than 20 and the department is also IT. Now let's just do some manipulation in the same query. So we will see for the OR operator. So here we will see the query for the OR operator. So we will be using the same query, and in the place of AND we will be using OR. So give me the details of all the employees whose age is greater than 20 or the department is IT. So it will search for all the employees whose age is greater than 20, either the department is IT. So let's just run this query. So once we run this query, we can see that we are seeing much more details this time. Like we are seeing the details of all the 5 employees, because for all the 5 employees the age is greater than 18. So it's not seeing for the second criteria, that is department equal to IT. On the basis of age is greater than 18, it is giving me all the results. Now let's see for the NOT operator. So for the NOT operator, we will give select star from employee, and then I want the details of all the employee where department not in either IT or HR. So give me the detail of all the employees where department is not either IT or HR. So let's just execute this query. So here you can see that I am getting the details of all the employees whose department is neither IT or HR. We are getting the department for marketing and finance. So it will basically give me the details of all the employees whose department doesn't lies in this particular list. So in operator basically checks that if in this particular list are there any department which is existing here or not. So if we are using in operator, let's see for the in operator how it works. So in operator. So for the in operator what we do is we give this command select star from employee, and then we want the details of all the employees whose department is IT or HR. So whose department is having values either IT or HR. Now you will say that why are we even using this in operator? We can use this or operator. We can provide department is equal to IT or department is equal to HR or department is equal to marketing. Yes, we can provide it here, but here it's very easy to provide because we can provide list of values. We can also provide those values which are not present even in this department column. So in makes us very easy to compare between the list of items and the item which is present in our column. So let's just execute this query. So here you can see that we are getting the employee details for all the employees whose department is either IT or HR, or basically the department which lies in this particular list. So whenever we give not in front of in, it basically makes sure that give me details of all the employee whose department is not in IT or HR. So it basically reverses the result which we get in using in operator. So now the next operator is null, is not null operator. So basically is null operator checks for the null values, is not null operator checks for the not null values. So whenever we want to check for any null or not null values, we can use this is null and is not null operator. So here you can see a query where we are checking that give me the details of all the employees where department is not null. So give me the details of all the employees where there is no null present in the department column. So it will give me the details of all the employees. So let's see for the not null operator or null operators. So here we will see about the not null, is null and not null operators. So give me the details of all the employees where department is not null. So let's just execute this query. And here you can see that we are getting the list of all the employees where department is not null. For now there are no null values which is present in department, but you can understand it in this way that if there are any null values for any particular record or any particular employee, it will not show that particular result. Now let's see the next operator, that is the bitwise operator. So there are two operators in bitwise. First one is and second one is OR. So in bitwise operator, what it does, it basically converts the integer value into bits and then perform any of the operation either and or on in this particular bits. So for now bitwise operators is not something which is very concerning to us. So for now we are skipping the query for this because it's not very used, but you can understand that in bitwise operator we convert the integer into bits and then we perform any of the operation like and or on the bits itself. Now the next operator is the like and the wildcard operator. Now what is this like and wildcard operator? Like operator is used to search for a specified pattern in a column. So whenever we want to search for a specified column, like give me the details of all the employees who are having double A in their name. Give me the detail of all the employees whose names start with A. So whenever we are trying to search for a pattern, we use this like or wildcard operator. It uses wildcard operators for matching patterns. So this like operator basically uses the wildcard operators for matching patterns. Now the very first wildcard operator is the % sign, which basically matches for any sequence of 0 or more characters. The query is given as select star from employee where name like. So here you can see the like operator is given and here we are provided A and %. So what does this mean? So it basically means give me the detail of all the employees whose name starts with A and can have many more characters after their name. So consider that a person is having a name as Abhay, a person is having a name as Aman, a person is having a name as Ayush. So all these employee names we can see because these all employee names start with A and have 0 or more set of characters after that. So basically like search for a specified pattern and returns the value whenever it matches any of the pattern which is given here. So if I give R and percent, so it will give me the details of all the employees whose names start with R and can have more characters in their name. Either it can be 0, either it can be 1, either it can be 2, or either it can be many. So Riti will also qualify for this, Ram will also qualify for this, Rahul will also qualify for this, because the number of characters after R does not matters because it is given as percent. So percent basically replaces all the characters and it will find that all the names start with R. So these qualify for this particular query. Now for the second wildcard we have underscore. So it matches for any single character. So here percentage matches for any set of characters. But if we are giving underscore, it means that there should be only a single character. So here you can see a query where I am getting all the details of employee, where name, like, and we have given a single character and A. So give me the details of all the employees whose second character in the name is having A. So first character can be R, can be A, can be B, can be C, anything. But the second character in the name should always be A. So it basically matches for a single character. Now let's see from a MySQL workbench and understand that how it's working. So let's use for the like operator. So we will use the like operator when we are using the wildcard as percent. Let's fetch all the details of employee whose name starts with A. So we will give select star from employee, and then we will give where, then we will provide name, and then we will provide this like operator, and inside the inverted comma we will provide the character for which we are searching, and then if there can be any number of characters or not. So we'll just execute this query, and once we execute this we can see that we are getting the details of all the employees whose name is starting with A. It doesn't matter that how long the name is, it doesn't matter that how many characters are there after A, but they are having the name as A in the very start. Now let's see for the like operator using the underscore wildcard. So we will give like operator when using a underscore wildcard. So let's get all the details of a person who is having the second letter or second character as A in their name. So select star from employee, and then we will give where, and then we'll provide name, and then we will give the like operator, and here we will leave the first character. First character can be anything, and then we will give the second character as A, and then we will give this percent sign that after the second character there can be many characters. So we will just execute this query. So once you execute this query, you can see that we are getting the details of two employees, Rahul and Raj, who are having A as the second character in their name. It doesn't matter what is the first character. It doesn't matter that how many more characters are there after A. We are getting the details of all the employees who are having A as the second character in their name. Now the next operator is the between operator. So between operator basically checks if the value is within a range of values. So consider that we have given a range of values, if our values lie between this range or not. So here you can see that we are trying to fetch all the details of a person whose salary lies between 1200 or 1500. So select all details from employee where the salary lies between 1200 and 1500. So let's see from the MySQL workbench. So we will see for the between operator. So let's fetch the details of all the employees whose salary lies between 1200 to 1500. Employee where salary between 1200 and 1500. So we'll just execute this query. So here you can see that we are getting the details of two employees whose salary is 1500. So basically this between operator is an inclusive operator. Basically it means that it will search for an employee who is having 1200 salary as well, and it will search for an employee who is having 1500 salary as well, and then any salary which lies in the range. So it includes this also and this also. So what are clauses in SQL? Clause basically means condition. So clauses are like tools or condition that help us to make queries more specific or decide what data we want to fetch. So whenever we want to fetch some data which is specific to some of the condition or specific to some of the clause, we use the clauses in SQL. So here we have mentioned all the type of clause which are there in SQL. So the very first one is where clause, which we know that which is used to filter out data. Now the second clause is the group by clause, the third clause is the having clause, the fourth clause is the order by clause, and the fifth clause is the limit clause. For the group by and having clause, we will learn about this after aggregate function, because this works on a aggregated set of data. But for where, order by and limit, we would be learning in this particular video only. Now the query for using a clause is we give select, and then we provide if we want to give any kind of condition on a given row, then we provide from, then we provide the table name, and then we provide the clause, and then we provide the condition. So whatever is the clause and whatever is the condition, perform all these on these particular columns. Now the very first clause is the where clause. Now where clause is basically used to filter the row based on the specified condition. So the query for the same is select column from table and where condition. So let's assume an example where I want to see or fetch all the details of a person whose age is greater than 20. So we are filtering out all the employees whose age is greater than 20. So we will give select star, that is all, from employee where age greater than 20. So it will give me the details of all the employee whose age is greater than 20 from a table employee where there could be multiple employees with the age 25, 26, 18, 17 and much more. Now the second clause is the limit clause. So the limit clause in SQL is used to restrict the number of rows returned by a query. So consider that I am writing a query for giving me all the details of a person whose age is greater than 20. But I want only 3 of the employees whose age is greater than 20. Or let's just understand in this way. Consider that there is a school. Now in that particular school there are 5 students who have scored above 90. But I want the details of only top 3 people who have scored above 90. So what I'll do, I'll just use this limit clause which will put a limit to the result which we have got. So this query retrieves the first n rows from the table. So whenever we provide a limit n, it will just give me the n rows from the table. Consider we provide the limit for 2 rows, so it will only return me the 2 rows, or 3 rows, then it will only give me the 3 rows. So here n can be 1, 2, 3, anything according to your condition or according to your use case. Now the query for the same is select column 1, column 2 or any of the column, or if you want all the details you can use the star, then from, then table name, and then here we provide limit, and then we provide the number of rows, like how many number of rows we want. Consider that we want to only see the details of 2 employees. So what we can do is select star from employee, and we can provide limit, and we can provide 2. So it will give me the details of only 2 employees from all the employees. So let's see from the MySQL workbench. So consider a condition where we want to only see the details of 2 employees. So what we will do is we will give select star from employee, and then we will give the clause, that is limit, and then we will give the condition, that is 2. So give me the details of only 2 employees. So let me just run this query. So here you can see that we have got the details of only 2 employees. So in this way limit clause work. So here we can provide the value either 2, 3, 4, 5 according to your use case. Basically limit sets the limit to the returned results. So consider that if I want to see the details of all the employees, it will return me the details of 5 employees. But in that particular 5 employees, I want to put a condition that give me the details of only 2 employees. So limit sets a limit on all the values which is returned. Now the next clause is the order by clause. Now the order by clause is used to sort the results in either ascending or descending order. So whenever we want our results to be sorted in either ascending or descending order, consider I want to see the details of all the employee whose salary is highest from lowest. So we can use this order by clause. Now by default it returns the result in ascending order. So if we haven't provided the order, it will by default return the result in ascending order. So this query retrieves the first n rows from the table. Now the query is select, and then we provide if there are any columns from which we want to see the data, and then we provide from, and then we provide the table name, and then we provide this order by clause, and then we provide the column, and then we provide either ascending or descending. So basically we provide the order by, and we want the order by to be performed on this particular column, and we want the results to be filtered in either ascending or descending order. So here you can see an example, select star, which basically means all, from the table name employee, and then we provide the clause order by, and then we provide the column in which we want the order by clause to be executed, that is salary, and then we provide the manner or the fashion in which we want to see the result, that is descending. So it will basically give me all the employee details with the salary in the descending order. So let's see from the MySQL workbench. So here we will be seeing about the order by clause. So we will use this select star from employee. We want to see the details of all the employee who is earning the salary from the highest to lowest. So we will select star from employee, which will give me the details of all the employees, and then I will put a clause order by, and then I'll provide from which column we want to order the details. So we will give salary, and then we will provide that in which manner we want to see the salary, that is in descending order. So let's just execute this query. So once I execute this query, here you can see that we are seeing the salary in the descending order, like the one who is earning the highest is at the very first, and the one who is earning the lowest is at the very last. If we don't give any manner like ascending or descending, it will by default take the ascending. So let's see without giving any order. So here you can see that by default it is giving me the results in ascending order. So this is all about the order by clause in SQL. Now let's do some practice question. So the very first question is write a SQL query to fetch the details of employees having ID as 1. So we have to write a SQL query where we have to fetch the details of employee who is having ID as 1. So we will write select, and then we will give all, and then we will provide from, and then we will provide the table name, and then we will provide the where clause, and then we will provide ID, and then we will provide a comparison operator, and then we will provide 1. So give me the details of all the employees where ID is equal to 1. So here we are seeing the use of where clause. Now let's go to the next question. So the next question is, write a SQL query to fetch the details of all the employees who are having ID as 1 and city as Mumbai. So give me the details of all the employees who is having ID as 1 and city as Mumbai. So here we'll be using this query, select star from employee where ID equal to 1, and because we are seeing that ID is also 1 and the city should also be Mumbai. So both the conditions should be true. So ID equal to 1 and city equal to Mumbai. Now the next question is, write a SQL query to fetch the details of employees who are having salary greater than 1200 and the city as Mumbai. So we want to fetch the details of all the employees who are having salary greater than 1200 and the city as Mumbai. So what we will do is we'll give this query select star, which basically means all, from employee. So it will fetch all the details of this employee table. Now on the all the details we have to perform some condition. So where salary should be greater than 1200 and city should be equal to Mumbai. So this is how we are writing this query for this particular practice question. Now the next practice question is, write a SQL query to fetch the details of employees who are not from Mumbai. So we want the details of all the employees who are not in Mumbai or not from Mumbai. So we will give this select star from employee, which will fetch me the details of all the employees. Then we will provide this where condition and we will provide city not in. So basically not in, make sure that in this particular list whatever thing is given is not present in the city column. So if this particular data is not present here, it will return me the details of that particular employee. So city not in, and here we provide Mumbai. Now the next practice question is, write a SQL query to fetch the details of employees having the maximum salary. So we have to write a query to fetch all the details of our employee who are having the maximum salary. So we'll give select star from employee. So here we'll get the details of all the employees, and then we will provide this order by clause, which basically makes sure to give the results in a certain order, and then we will provide which column we want to order, that is the salary. So we will give the salary column, and here we want the maximum salary, so we will provide the order as descending. So in the descending order we'll get the maximum salary as the very first record. Now the next query is, write a SQL query to fetch the detail of 2 employees who are having the maximum salary. So here we have to break the problem, is we have to fetch the detail of only 2 employees who are having maximum salary. So for the maximum salary we can use the order by clause followed by the descending order on the salary column, and for the 2 employees we can use the limit clause. So what we will do is we will write the query is select star from employee, and then we will try to fetch the maximum salary. So we will give order by, and then on which particular column you want to order, that is salary, and then in which manner you want to get the details of salary, that is descending, and then we will limit that particular result which we get from here to 2 employees. So in this way we can get the details of 2 employees who are having the maximum salary. So this was all about the practice question and clauses in SQL. We will learn about group by and having clause in next set of videos. So what does this aggregate means? Aggregate basically means collated. So all the functions or all the methods which is helping us to do some manipulations or do some calculations on a collated or collected set of data, that is called as aggregated function. So let's see the definition. So aggregate function performs some operation on a set of rows, you can say collection of rows, and then returns a single value summarizing the data. These are used with select statements to perform calculation. Now let's understand from an example. Consider that you have an employee table with you. And now in this employee table you have some columns such as ID, salary, employee name. Now there are many employee data which are feeded inside the system. For now consider that we have feeded 3 employee details, employee E1, employee E2 and employee E3. Now if we want any kind of manipulation or any kind of value from the given set of data or from the collated set of rows, we use the aggregated function. Now what kind of value we would be desiring? So consider that I want to find that what is the maximum salary a person is getting from all the employees. So we can use the max function which is present in aggregate function. If I want to know that what is the minimum salary employee is getting in the company, so we can use the minimum function. What if I want to know the average salary company is giving to our employee? So we can know the average salary by collating all the data which is present in the row and doing manipulation on all the salary which is present there. In the same way we can know the total salary using the sum function. Also we can count how many employees are there using the count function. So as you can see that this particular minimum function will first go to employee E1. It will see that what is the data present. It will take the data. Consider the salary is 1200. Now in the employee E2 it will go and see if the salary is less than 1200. If it's 1300 it will ignore this. Then it will go to E3. It will see if the salary is less than 1200. It's 1100. So now it will erase this 1200 and have 1100 in the output. Now it will go to the fourth column, see if the salary is less than 1100. 1100, so it's 1500, so it will ignore this. So the final output we will get is 1100. So the minimum salary of an employee in this particular employee table or in a company is 1100. In the same way, it can calculate the maximum value. When it wants to calculate the sum of entire salary, it will just add the salaries of employee E1, E2, E3, E4, and it will get the total salary which the company is giving to the employees. Now, there are many types of aggregated function, as I told here: min, max, average salary, sum. So let's see about them. So the first one is count, which basically help us to count all the rows which is present in our table. The second one is sum, which is basically used to sum all the numeric values which is present in our table or in our column. The third one is average, which gives us the average of a particular aggregate or collated set of rows. The fourth one is minimum, which gives us the minimum value in a collated set of rows. The fifth one is maximum, which gives us the maximum value in the collated set of rows. And the sixth one is group concat, which is basically used to concat two groups. Now let's see about each and every aggregated function one by one. So the very first aggregated function is count. Now what is count? It counts the number of rows in a table or the number of non-null values in a column. So consider that in my table there are some columns and I want to count that how many people are there who are getting salary. So the salary details for each and every employee is feeded. Consider it is A, B and C here. So it will count 1, 2 and 3. So it will result the value as 3. That 3 employees are there in the company who are getting a salary. If there is a null value which is present here, like employee has joined the company recently but it hasn't been paid yet. So for this it will ignore this value and it will only give the 3 values. So it counts the number of rows in a table or the number of non-null values in a column. So basically in a column, if there are any non-null values, it counts the value and returns the output. So the query for the same is select, then we give the count, and then we provide in which column we are providing this particular aggregate function, and then we give from, and then we provide the table name, that is employee. So this will tell us the number of employees in a company. So we are giving a count on the name. So basically it will count all the name of employees and it will tell me, okay, in your company there are X number of employees who are working. So let's see from the MySQL workbench that how this count aggregate function is working. So for now, we will learn about the count function. So now what count function will do is, let's see that what all details are there in our employee table. So we will just execute select start from employee to see all the details. Now here you can see that there is ID, name, age, department, city and salary. Now I want to count the number of employees in my company. So what I'll do is, I'll give this command as select, and then I'll provide the aggregate function, that is count. And then I'll provide that which particular column I want to count. So I can get the count of employee using the ID, name, age, department, city, salary, any of the columns. But for now, let's take the name column because name is something like all the employee would be having a name. So let's calculate from the name column only. So we'll give name, select count name, and then we will provide from and the table name from which we are trying to find the count employee. And let's just execute this data. So here you are seeing that we are getting the count as 5. So we have feeded the details for 5 of the employees and we are getting that in your company there are 5 employees who are existing. Now let's see the second aggregate function, that is sum. So what is sum? Sum basically calculate the sum of all the values which is present in a numeric column. So whenever there is a column which is having numeric values, we can use this sum function. Consider salary. So this adds up all the number which is present in the list. So if in the list of all the rows which is present inside a column, it adds up all the salary and gives us the desired salary or the total salary. So here you can see we have provided a query where we are giving select, and then we are providing the aggregate function, and then we are providing the column on which we are taking the aggregate function, that is salary, and then we are providing from, and then we are providing employee. So this particular query will give me the total amount company is paying to its employee. So it will tell me the total amount which the company is paying to its employee so that the company can make their budget. So let's go to the MySQL workbench and see how the sum aggregate function is working. So we will just do select, and then we will give sum, the aggregate function, and on which particular column we want the sum. So we will give salary, and then we will give from, and then we will give the table name, that is employee. So let's just execute this query. So here you can see that we are getting the total sum of all the salaries which were present in the salary column. So this works the same way on how we are trying to fetch the details from the table. It's just that while fetching the details, like while fetching any of the column, we are providing an aggregate function to get a collated data or to get a collated result of all the rows which is present inside our column or all the records which is present in a single column. Now let's go ahead with the third aggregate function, that is average. Now it computes the average of all the values in a numeric column. Again, for average also we need a column to be numeric. It can't hold any varchar or string values. It needs to have a numeric value. And whenever we want the average of all the numeric values, we can use this average function. Now it finds the average or the middle number of the numbers in a list. So consider that company wants to know that what is the average salary they are giving to the employees. So they can use this average function, which can tell you, okay, this is the average salary a company is giving to their employees, or this is the average fees we are getting from the students. You can take that example as well. So here you can see the query where we are getting select, and then we are giving the aggregate function, that is average. Then we are providing the column on which we are doing this aggregate function, that is salary. And then we are giving from, and then we are providing the table name, that is employee. Now this query will tell the average amount company is paying to its employee. So let's see the average function as well. So we will see for the average function, the average salary company is giving to its employees. So we will give select average, and then we will provide the column name, that is salary. So always make sure that these functions like salary, sum, it works only on the numeric columns. So you can't use that in a column which is having varchar or string values. So average salary, and then we can give from, and then we provide the table name, that is employee. So let's just execute this query. So here you can see we are getting the average salary a company is paying to their employees. So let's look at the fourth aggregate function, that is minimum. So minimum help us to find the smallest number in a list. So whenever there is a list and we want to find the minimum value or the minimum salary company is giving to its employee, we can use this minimum function. In the same way, we can also use a maximum function which tells us the maximum value in a particular column. So this minimum function tells us the minimum value, that is min, tell us the minimum value, and max, that is maximum, tell us the maximum value. So here you can see the query we have given. Select, and then we provide the aggregate function, that is minimum, and then the column on which we are providing this aggregate function, that is salary, and then we provide from and which table name, that is employee. So this will tell the minimum salary company is paying to its employee. And in the maximum, we do the same query. It's just that minimum is replaced by maximum. So we give select max, and then we provide the column name, that is salary, and then we provide from, and then we provide the table name, that is employee. So this will tell the maximum salary company is paying to its employees. So let's go to the MySQL workbench and see how it's working. So the next aggregate function is minimum. So we will give the query as select minimum, and then we will provide the column name, that is salary, and then we will provide from, and then we will provide the table name, that is employee. So let's execute this query. So once you execute, you can see that you are getting the minimum salary as 1500. Let's just verify if 1500 is the minimum or not. So let's see all the details of this employee table. So here you can see that the salary is 1500, 2000, 2500, 2400, and 1500. So 1500 is the minimum salary which is present in our employee table. And in the same way, we can find the maximum salary as well. So we have to just replace minimum with maximum, that is max. So we'll just replace minimum with maximum, and we will just execute this query. So once we execute, we can see the maximum salary is 2500. Let's just verify from our table details also that if the maximum salary is 2500 or not. So if we run this query, we can see that there is 1500, 2000, 2500, 2400, and 1500. So from here also we can verify that 2500 is the maximum salary which our employee is getting. So while we were learning about clauses in SQL, I left these two clauses, group by and having clause. So let's know that why I left both of that clauses, and let's see that how are they helping us. So what is this group by clause? So whenever we want to group data, we use the group by clause. So this clause is used to group rows that have same values into together. It helps to organize data into groups so that they can do calculations like finding totals, averages for each group. So in the last particular video of aggregated function, we learned that if we want to perform any operation or any function on some collated set of data, we use the aggregated function. Consider that there is a salary column in my employee table. If I want to know the minimum salary among all the particular rows which are present in my table, we can use the minimum function. If I want to know the maximum salary, we can use the maximum function, which will see in all the rows and give a single result on this collated set of rows. Now how this group by clause help us? So consider that for now we were finding the salary, the minimum and maximum salary for all the employees, but consider that there are some departments in the employee. So one is the IT department, one is the HR department, one is the marketing department. Now what if I want to know the minimum salary in the IT department or the maximum salary people are getting in the HR department? In IT we have 2 employees, E1 and E2. In HR we have 2 employees, E3 and E4. In marketing we have 3 employees, E5, E6 and E7. So earlier what it used to do in aggregate function, it used to see for all the employees E1, E2, E3, E4, E5, E6, E7 and used to provide us the minimum and the maximum salaries. But now what will happen that it will see only in a group of data. Like only in the IT department there are 2 employees, among the 2 employees give me the minimum salary, or among the 3 employees in the marketing department give me the maximum salary. So you can see that how we are working on a group of data. So this can be achieved using the group by clause. Now the query retrieves the first n rows from the table. So let's see the query. So the first is select, and then we provide the column name on basis of which we are grouping all the rows. So basically here we are grouping the rows on the basis of department. So we will provide department on, like, basically the column name on basis of which we are grouping all the things. Now then we will provide the aggregate function, and then we will provide the column on which we are providing the aggregate function. Like I am grouping all the fields based on department. Now in the department they are grouped into IT, HR and marketing, and now in the department we are finding this minimum or maximum using the salary. So salary is basically the column on which we are using the aggregated function, in which we are trying to get the collated data, and then we are also grouping the all the values on basis of the department. So basically we provide the aggregated function, then we provide the column 2, that is salary, and then we give from, and then we provide table name, and then we provide this group by clause, and then we provide the column on basis of which we are grouping the elements, that is column 1. So here you can see that an example is given here where I am selecting department, and then I am giving the aggregate function average, and then I am providing on which column I am using the aggregate function, that is salary. And here you can see that I have given a as. So basically what as does is it will calculate the average salary, and it will create another column with the name average salary, and it will show all the details which is present here. And then we give from, and then we provide employee, and then we provide the group by clause, and then we provide the column on basis of which we are grouping the elements. This is how the group by clause work. If you are still not understanding that how the group by clause work, let's just understand it again. So let me just clear all the data which is present here, and we will then see that how this group by clause is working. So let's take an example. Consider that there is a table of employee. Now in this employee table we have department and salary. For now I am only taking 2 columns just to make it a bit simpler, and then here are the details of some of the employees. So one of the employee is in IT department, the next employee is also in IT department, one is in HR, one is in marketing. Let's take one more. So that is also in HR. And now the salaries are 1100, 1200, 1100, 1500, 1100. Now what this particular query will do? So what it will do, it will select department. Now it will select the department column. So it will select the salary column as well. Now what it will do, it will group by the department. So what it will do, it will make the group of departments. So the very first group which will be present will be of IT. Now IT is having 1100 as salary and 1200 as salary for 2 of the employees. Then it will make a group of the HR department. Basically the similar values will be together. So IT both are similar, so that will be in one group. Now HR, are we finding any HR? So HR is also present here. So we have 2 values for HR as well. First is 1100, second one is also 1100. Now the next one is marketing. Is there any group for marketing present? No. So there is only one employee in marketing, that is 1500. So we have formed 3 groups, IT, HR and marketing, and we have given the respective salary of all these 3 groups. Now what it will do, now it will perform this aggregate function which is average salary. So what it will do, it will find the average salary between these 2 employees, and it will give a single result of the average salary for IT department. Then it will perform the aggregated function on these 2 groups, and then it will provide the average salary for the HR department. Now it will do like there is a single element, so it won't do much of the thing. So it will just provide the average salary of the marketing department, which will be 1500 only. So in this way we can find the average salary per department. So in this way we are trying to group the data, and in this way we are trying to aggregate the data and perform some aggregated functions on the data. So let's see from the MySQL workbench, then it would be more clear from there. So let's go to the MySQL workbench. So let's see that how group by clause is working. So what I'll do is I'll give the command select, and then I'll select department because I want to group them on the basis of department, and then I will give that what I want to do the aggregated function on. So basically I want to do the aggregated function on salary. I'll give this average salary, and then I'll give from, and then I'll provide the table name, that is employee, and then I'll provide the group by clause, group by, and then I'll provide the column name on the basis of which we are grouping the elements. So we are providing as department. Now in the query, if you remember, I've provided this as, and then I've provided a new name, that is average salary. So let's see that what it will do. So I'll provide as, and then I'll provide a average salary column, like a new column name. So let's just execute this query. So here you can see that we are getting department as IT, HR, marketing, finance, and here you can see that a new column with the name average salary is having all the values of the average of IT, the average of HR department, the average of marketing, and the average of finance. So in this way this as function works. So the next one is the having clause. So the having clause is just like the where clause, but the main difference is it works on aggregated data. So where clause can work on non-aggregated data, but having clause is something which only works on an aggregated data or collated set of data. So it is used with the group by clause, and it helps to filter groups based on a given condition. So consider that if you want to give some condition during grouping of the elements, we can use the having clause. Earlier, whenever we want to provide any condition, we were using the where clause, but whenever we are providing any condition on a collated set of data or aggregated set of data, we use the having clause. So here you can see the query. So we give select, and then we provide the column on basis of which we are grouping the data. Then we provide another column on basis of which if we want to group the data on basis of two columns, so we provide both the columns, and then we provide the aggregated function, and then we provide the column 3. The column on which we are aggregating the data, and then we provide this from, and then we provide the table name, and then we provide this group by clause, and then we provide like on which columns we are grouping, so column 1 and column 2, and then we provide this having clause, and here we provide the condition. So whenever I want to provide any condition during group by clause or in aggregated function, we use this having clause. Now here you can see that we have given an example where what we are doing is we are selecting the department and we are taking the average salary as salary. So basically we are grouping all the departments and we are taking the average salary from all the departments. So from here we give the table name, that is employee. Here what we are doing is we are grouping all the rows which are present in our columns into a single collated groups, like IT is having one group, HR is having one group, finance is having one group, basically all the similar type of elements in one group. And then here we are giving a having and average salary is greater than 1500. So here we are providing a condition. So what it will do, it will first group the departments. So it will group the department into different departments like IT, HR and finance. Now for each and every department, it will find the average salary and average salary. And at the last, it will check that if the average salary is greater than 1500 or not. If the average salary is greater than 1500, it will show this particular result in output. If the average salary is not greater than 1500, it will not show the given result in output. Same goes with the HR department and same goes with the finance department. So let's see from the MySQL workbench that how this having clause is working and how it is helping us to provide conditions. So we will give having clause. So here what we are doing is we are collating all the given rows of the column department into some single groups, and in that particular groups we are trying to find the average salary. After finding the average salary of each group, we are checking that if the average salary is greater than 1500 or not. So let's see how it works. So we will give select, and then we will give department, and then we provide the aggregated function, and then we provide the column name in which we want the aggregated function, that is salary, and then we provide this as average salary to show it in a different column. Then we provide from, and then we provide employee, and then we provide how we want to group the data, so group by, and then we provide the column name, that is department, and then here we provide the clause, having clause, so having, and then we provide the condition. So here we have renamed the average salary as AVJSALARY, so we will use this particular column name and we will just give average salary is greater than 1500, and let's just execute this query. So once you execute this query, you can see that we are getting only the department of IT, HR and marketing with the average salary as 2000, 2000 and 2400. So all the average salaries which are present in this particular column are greater than 1500. What if we don't give this having clause and we see that what is the average salary per department? So if you run this query, so you can see that there is a finance department also which is having an average salary as 1500. But we are not able to see the finance department in this particular query because we have given a check that average salary or a condition that average salary should always be greater than 1500. What if I give it as greater than or equal to 1500? So let's see if we are able to see the finance department now or not. So if I run this query, here you can see that we are seeing the details of the finance department also. Let's see all the departments who is having average salary greater than 2000. So we will be only seeing one result. So let's see. So here you can see that we are seeing only one department, that is marketing, that is having average salary greater than 2000. So this is how the group by and the having clause work. Having clause is mostly used with the aggregated function, and it's just like the where clause, we provide the condition in the having clause. Group by clause is mostly used with the aggregated function whenever we want to collate all the rows into a particular group who are having the same values. So consider in department, if there are 5 IT department, we can group all the IT department into one single group. Like if in a school database there are many classes, class 1, class 2, class 3, we can group class 1 into one group, class 2 into one group, class 3 into one group, and then we can see that what is the average fees class 1 is giving, what is the average fee class 2 student are giving, what is the average fee class 3 student are giving. Now in the next set of video, we would be seeing about some practice question which would be helping us to get ourselves familiar with the group by, order by, having and limit clauses. So when I was teaching about this having clause, many people had a doubt that why are we even knowing about this having clause, like what this having clause is doing. Having clause is basically helping us to filter out data based on a given condition. So was the where clause. Then what was the need of having clause? So what is the where clause? Where clause is a clause which is basically used to filter rows from the result based on a condition applied to a row before aggregation. So whenever we want a filtered data based on a given condition from a table, we use the where clause. But where clause is always used before aggregation. Now what is this aggregation? So aggregation, or you can say aggregate functions, are the functions which work on some collated or collected set of data and returns a single value based on some manipulations. Like if we want to find the maximum salary, if we want to find the minimum salary among all the employees, we can use the aggregate function. So aggregate function mostly works on a collated or collected set of rows. So whenever we want to work on some collected or collated set of rows, we use the aggregate function. And here it is saying that where clause is a clause which should always be used before the aggregate functions. It means that we should always be using it on an individual rows, not some group of rows or collected rows. Now what is having clause? So having clause is a clause which is used to filter rows from the result based on a condition applied to a row after aggregation. So whenever we have formed a group, such as like there is a group of IT department people, there is a group of HR department people, there is a group of marketing department people. Now in this particular groups, if we want to provide any condition to filter out some data, we use the having clause. So where clause is mostly used before the aggregate functions, and having clause is mostly used with the aggregate function. Now where clause is mostly used with the select, update and delete SQL commands, whereas having clause is mostly used with the group by clause and the aggregate function. Now what we do is we form some groups. On that particular groups we perform some aggregate functions, and this aggregate functions returns us a single value, and on that particular value we perform any condition using the having clause. So having clause is mostly used with the group by clause along with aggregate functions. Now the query for the where clause is select, and then we provide star, which basically means all, and then we provide from, and then we provide the table name from which we are making the query, and then we provide this where followed by the condition. In having we mostly give select, and then we provide the columns on which we are grouping the data, then we provide the aggregate function, and then the column on which we are performing the aggregate function, then we give from, and then we provide the table name on which we are performing the having clause, and then we provide the group by, and then the columns on which we are grouping the data, that is column 1 and column 2, and then we provide this having, and then we provide the condition. So having clause mostly works with the group by clause and the aggregate functions, whereas where clause mostly works with the select, update, delete commands. Where clause is oftenly used whenever we want to filter out some data based on some condition before the aggregation happens, whereas having clause is mostly used to filter out data based on some given condition after the aggregation happens. So this was the basic differences between where and having clause. So the very first practice question is, write a query to find the total number of employees in each city. So what we have to do is we have to find the total number of employees which are present in each city. So let's just break the question and then we will see how the query works. So first we have to find the total number of employees. So to find the total number of employees, here we can use the aggregate function. So in the aggregate function, we can use the count function, which basically counts the number of employees or counts the number of rows which are present. So this will help me to find the total number of employees. Now the second sub part is in each city. So what I have to do is I have to find the total number of employee in each city. So there could be multiple cities like Mumbai, Bangalore, Hyderabad and much more. Now I have to find the total number of employees who are present in each city. So there could be a possibility there are 2 or 3 employees who are living in the same city. So what we will do is we will here use the group by clause. So basically this clause will help me to group all the data which is present in Mumbai, which is present in Bangalore, which is present in Hyderabad. And then in these group of employees, we will count all the employees which are present in this particular cities. So what we will do is we will give this select, and then we will provide the column on basis of which we want to group the data, that is city, because here it is given in each city. So we will give city, and then we will provide the aggregate function count, and then we have to provide the column name on which we want to count. So we can either count on the basis of name, ID, salary and much more things. So for now we will use the name, and then there is as, and then there is a temporary column name or an alias name for this particular column. So what it will do is this count name will provide me a result or a value, and that particular value would be shown in this number of employees. So it is kind of acting as an alias for a particular column name. Now then we will provide from, and then we will provide the table name from which we want the specific results, and then we will provide the group by clause, and then we will provide the column name on basis of which we want to group the data. So this will help me to find the count of employees, and this will help me to group all the employees on a particular city. So these both together will help me to find the count of employees who are in each city. Now let's see from the MySQL workbench at how this query is working. So to understand all those queries, I have already created a company database. Inside that company database, I have already created an employee table, and in this particular employee table, we would be performing all the queries. So let's just see what are all the details which are present in this employee table. So we'll just execute this query, and here you can see that I've feeded the data of almost 5 employees with their name, age, department, city and salary. Now the very first practice question is we want to find the total number of employees in each city. So for that we will give the query as select, and then we'll provide the column name on basis of which we want to group the data, that is city, and then I'll provide the column name on which I want to perform the aggregate function, basically count the total number of employees. So I'll give name, and then I'll provide an alias for this particular column name as number of employees, and then I'll provide group by, and then I'll provide the table name, so from employee, and then I'll provide the group by clause which will help me to group the cities into some subgroups. So I'll give group by city. So let's just execute this query. So here you can see that we have got the city and we have got the number of employees who are there in each city. So for Mumbai there are 2, for Pune 1, for Surat 1 and for Indore 1. So this particular query will help me to find the total number of employees who are present in each city. Now let's see the next practice question. Write a query to find the maximum salary of employees in each city in descending order. So we have to find the maximum salary of employees in each city and then we have to order it in descending order. So let's just break this particular question into some sub questions and then we will write the query. So first what we have to do is we have to find the maximum salary of employee. So to find the maximum salary of employee we can use the aggregate function max, and here we can provide the column on basis of which we want to aggregate the data, that is salary. Now the next set says that in each city we have to find the maximum salary of employee in each city. So to get the group of cities we can use the group by clause. So here we'll use the group by clause on city, which will help me to get all the subgroups of city or all the cities into some similar subgroup. So let's see the query. So here in the query we have provided select, and then we have provided the column on basis of which we want to group the data, that is city, and then we have provided an aggregate function max on the column on which we want to get the aggregated data, that is salary, and then we have provided an alias for this column name as max salary. Then we provide the from, and then we provide the table name from which we want this particular data, and then we provide this group by clause, and then we provide the column name on which we are grouping the data, that is city, and then we provide the order by clause followed by the column name on which we want to order the data. So I've missed it here. So the column name would be max salary, because I have already created a max salary column name which is having all the maximum salary from the particular group. So we'll provide the column name as max salary, and then we will provide the manner in which we want our data, that is descending. So let's see from the MySQL workbench. So here if we want to find the maximum salary of employees in each city in descending order. So what we will do is we'll give the query as select, and then we'll provide the column name on basis of which we are grouping the data, that is city, and then I'll provide the aggregate function, and then I'll provide the column on which we are aggregating the data, that is salary, and then I can provide an alias for this, that is as, let's give it as max salary, and then I'll provide the table name, that is from employee, and then I'll provide the group by clause, so group by, and then I'll provide the column on which we are grouping the data, that is city, and now we want to see all our result in descending order. So we will be using this order by clause, so we will use order by, and then we can use this particular column name because it has all the aggregated set of data for each city. So we would be using max salary, and then we'll provide the manner in which I want to see my results. So select, then the column name on basis of which we are grouping the data, then the aggregate function on the column name on which we want the aggregated data such as maximum salary, and then we can provide an alias for that particular column, then we'll provide the table name, then we'll provide the group by clause followed by the column name on basis of which we are grouping the data, then we can use this order by clause to get our particular result in descending order. So here you can see that we are getting an error. The reason behind getting this error is in the earlier query we haven't ended the query, so here we'll provide a semicolon and you can see the error is gone now. Now let's just execute this query. So here you can see we are getting all the groups of city, and here we are getting the maximum salary in all the groups, and the maximum salary is sorted in descending orders. So this is how we can group the data and get the result in some specific order. So let's see the next query. So the next query is write a query to display the department names alongside the total count of employees in each department, sorting the results by the total number of employees in descending order. So what we have to do is we have to display the department names. So we have to display the department names which are present in our employee table. So we'll use the group by clause. Now alongside that we have to display the total number of employees in each department. So we have to tell that if there are 3 departments, IT, HR and marketing, now in this particular department how many employees are there. So for that we can use the count aggregate function to get the count of all the employees who are present in each department, and then we have to sort the result of total number of employees in descending order. So we have to sort the result of this total number of employees in descending order. So we can use the order by clause. So whatever result we get from this count aggregate function on some specific group of departments, we have to order the result on basis of that. So whatever is the result from this count, we have to order our results on basis of that. So we have to use the group by clause for the department name, then we have to use this count aggregate function to find the total number of employees, and then we have to order our results based on the result we get from count for each particular department. So very first we will provide the select command to make some query, and then we will provide the column name on basis of which we want to group our data. So basically it's department names, and then we'll provide the aggregate function, and then we'll provide the column on basis of which we want to perform this aggregate function. So here we want to find the total number of employees or total count of employees. So we'll use the count aggregate function, and then we'll provide a column name on which it will count all the total number of employees in each department, and then we'll give an alias for this as total employees. Then we'll provide the table name, that is employee, and then we'll provide the group by clause followed by the column name on basis of which we are grouping the data, that is department, and then we'll provide the order by clause, and then we'll provide the particular column on which we want to order our data, that is total number of employees, and then we'll provide the manner in which we want to order our data, that is descending order. So let's see from the MySQL workbench. We'll give the command as select, and then we want to group department into subgroups, and then we will provide the aggregate function, that is we want to count the total number of employees, and then we'll provide the column name on basis of which we want to perform our aggregated function, and then we'll provide an alias for this, that is total employees, and then we'll provide the table name on which we want to perform these operation, that is employee, and then we will provide the group by clause followed by the column name on which we are grouping the data, that is department, and then we will provide the order by clause followed by the column name on which we are ordering the data, that is total number of employees, so that is total EMP, and then we will provide the manner in which we want our data, that is descending. So let's just execute this query. So here you can see that we are getting all the department, that is IT, HR, marketing and finance, and here we are getting the total employees in each department. Now here you can see that all the result has been sorted in descending order, like IT is having 2 employees, so it is at the very first, and then all other departments are having 1 employee, so they are sorted on basis of that. Let's see the next practice question. Write a query to list the departments where average salary is greater than 1200. Also display the department name and the average salary. So we have to write a query to list all the departments where average salary is greater than 1200. So firstly we have to list all the departments, so we'll be using the group by clause for the same, and we'll be grouping the data on the basis of department. So we have grouped the data, we have listed all the department, then we have to find the average salary greater than 1200. So then we have to find the average salary for all the departments, so we can use this AVJ function from the aggregate function, which will help me to find the average salary for each department. So it will give me the value of average salary for consider IT, HR, marketing department. Now there is a condition that we have to find the details of employees who are having average salary greater than 1200. So from here we'll be getting a result, and here we'll be using the having clause as we are providing a condition to filter our data. So we'll be using the having clause, and with the having clause we'll provide the average salary greater than 1200. That is result of average salary for each particular department should be greater than 1500. So we have to display the department name as well as average salary. So let's see the query. So first we'll give the select command to make a query, and then we'll provide the column on which we are grouping the data, that is department, and then we'll provide the aggregate function, and then we'll provide the column on which we want to aggregate our data, that is salary. So here you can see that we are doing some condition or performing some condition on the average salary. So we have to find the average salary first, and then we'll provide an alias followed by the column name for which we are providing an alias, and then we'll provide from and then the table name, and then we'll provide the group by clause followed by the column name on which we are grouping the data, and then here we'll be using having clause because having clause is mostly used with the aggregated set of data. So here we have already aggregated some set of data, and here we want a condition that is average salary is greater than 1200. So we'll provide the having clause, and then here we'll provide the average salary, and here sorry, it's by mistake written as 5000, so the average salary should be greater than 1200. Either here we can provide this AVJ salary, or we can use the alias name, that is average salary as well. So in this way what it will do is it will group the department into some sub-departments or subgroups, that is IT, HR and marketing. Then it will find the average salary of all the employees which are present in IT, average salary, and for HR and for marketing. And when we have got the average salary for all the groups, then we will perform the having clause, that is having, and then we'll provide the condition, that is average salary should be greater than 1200. Sorry, here also I have by mistakenly told that average salary should be greater than 1500, so it would be 1200. So we have to find the list of departments where average salary is greater than 1200. So let's see from the MySQL workbench. So we'll just write a query. So we'll give select, and then we will give the column name on basis of which we want to group the data, that is department, and then we'll provide the aggregate function. So basically we want the average salary, so we'll use average, and then we'll provide salary, and then we'll give an alias, that is average salary, and then we will provide the table name, so from employee, and then we'll provide the group by clause to group our departments. So we'll provide group by and then department. So our department have been grouped. Now we want to provide some condition to the group data, so we'll provide having, and then we'll provide the column, that is average salary, and then we'll provide the condition that is greater than 1200. So show me the department of all the employees who are having average salary as greater than 1200. So let's just execute this query. So here you can see that you can see 4 departments: IT, HR, marketing and finance, and here you can see the average salary that is greater than 1200, greater than 1200, greater than 1200 and greater than 1200. So this was all about the practice question in this particular video. These practice questions are very important, so try to practice this, try to break the questions into sub questions and try to make query from the sub question. So here you can see that I have provided a table in which I have provided the rank in which we should be using all the particular commands, and then we have provided the commands, and then we have provided the use case for that particular command. So it's not possible that you are providing a condition to any of the column or any of the set of rows before even telling the MySQL server that these are the columns on which I want to provide the condition. So where can never happen before the select command. So first command is the select command. So select command is basically used to retrieve data from the database. So the very first thing what we do is we first retrieve the data from the database. Then now the next is from command, which help us to identify the table. Now in a particular database there could be multiple tables, so I need to tell my database that from this particular database I want this particular table. The third one is where clause, which help us to provide any condition or filter the rows based on some specific condition. So we have retrieved the data from the database, we have provided the table from which we are retrieving the data, then we can provide the conditions on that particular data which we are retrieving. Then the fourth one is group by clause, which basically works on the aggregate function. So if we want to perform any aggregate function, we can use this group by clause after where. Why we are using this group by clause after where? Because where is mostly used before the aggregated function and having is mostly used after the aggregated function. So using the group by clause, we can group the rows that have the same values based on some aggregate function, and then we can use this having clause, which help us to filter groups based on some condition. So where clause help us to filter rows based on some condition, whereas having clause help us to filter groups based on some condition. And then at the 6th number we have the order by clause. So we have retrieved the data, we have identified the table, we have filtered some rows on the table, we have grouped the rows, we have filtered some group on some basic condition, and then we want to sort the result either in ascending or descending order. So we can use the order by clause. And at the very last is the limit. We have retrieved the data, we have filtered the rows, then we have grouped the data, then we have filtered the groups, then we have sorted the result. Now I want to limit the number of rows which are result in our final result. So this is the general order of SQL commands which we follow while making any of the queries in SQL. So what is joins in SQL? As the name suggests, join. So basically we are joining something to get a desired result. So joins are used to combine rows from 2 or more tables based on a related or shared or common column between them. So whenever we have 2 or 3 tables who have a related or a common column between them, like consider an example of ID. So the ID column is present in the student table, the course table and the course details table as well. So that particular ID column is a shared or a common column between all those 3 tables. So we can just join them and get all the related details we want from all these 3 tables. There are commonly 4 types of joins. So the very first one is inner join. Then there is an outer join, which consists of left join, right join and full join. And then there is a self join, and then there is a cross join. Now in these particular tables you can see there is a student table and then there is a course table. In the student table also we have an ID column. In the course table also we have an ID column. So since they both have a common or a shared or a related column, we can perform join operations on them to get the details of name, age, course ID, course name for a particular student. Now as I told that there is a shared or common column between these 2 tables. So there would be a doubt which would be coming to your mind is कि whenever there is a common column between 2 tables, we establish a relationship using foreign keys. So is foreign key important for performing joins? So the answer is join can be performed based on any column that establishes a relationship between 2 tables, not just foreign key constraints. So it's not necessary. So it's not necessary to have foreign key present in one of the table. Even if there is no foreign key, but there is a column which is kind of present in another table as well, we can perform the join operation. So foreign key is not a must have. If 2 tables are having a foreign key relationship, we can perform join on them. If there is no foreign key present in any of the table, still we can perform join operation on them because we only need a shared or a common column between 2 tables. Now let's see on the types of join. So the very first join is the inner join. Now as the name suggests, inner join. So basically we are trying to fetch all the inner details from 2 tables. So there is table 1 and table 2, that is A and B. Now in this particular table A, we are calling it as left table. The table B, we are calling it as right table. So whenever we perform inner join among any 2 tables A or B, we get the common values between them in the inner join. So basically the values which are present in left table as well as the values which is present in right table, we get the value as result whenever we perform the inner join. So here you can see that there are 2 tables, student and course. So if we want to perform any inner join among them, what it will do is it will search for the common column. So the common column is roll number. Now in that particular common column, it will find the values which is common among both of the tables. So 1, is there any value of 1 here? So it would be discarded. Then 2, is there any value of 2 here? Yes, so we we will be printing 2 Hindi along with 2 Rahul whenever we perform an inner join. And then 3, there is a row with the value as 3, so we will be printing 3 Riti along with the subject as English. So in this way we get the common values which is present between left table as well as the right table. Now the second join is the left join, or we can also call it as left outer join. Now in the left outer join, what happens is if we get all the values which is present in left table along with the values which is present in left and right both of the table. So basically we get all the values which is present in left table. So consider for now student is the left table and course is the right table. So we will be getting all the values which is present in left table, that is 1, 2 and 3, and we will print the name for all the 3, and then we will come to this particular table. So here we can't find the roll number 1, so for now null would be assigned to that particular person Ram, and then for 2 we can get Hindi, and then for 3 we can get English. So mostly we will be first taking all the values of the left table, and then we will be seeing that in this particular left table what are the values which are common in the right table, and we will be taking that. Now the third one is right join or right outer join. So it is kind of similar with the left outer join. There is just one difference, that in this particular join we take all the values from the right table along with the common values between the left and the right table. So if this is the left table and this is the right table, we will be taking all the values which is present in that right table, and then we will find the common values which is present in the left table, and then we will display all the particular details. But in the right table you can see a roll number 4 who has opted maths, but here you can't find the roll number 4. So for that particular column we will fill null in the name. So mostly in the left and right outer join, whenever it doesn't find any values in the next column, it just fill the null value. Now the fourth join is the full join or full outer join. In this particular join we take all the values of left table, right table along with the common values between them. So all the values which is present in left table would be taken, all the values which is present in right table would be taken, and all the values which is common between them would be taken. So if there is 2 tables left and right, so we will take all the values which is present in student table, we will also take all the values which is present in course table. Now for the course table, the values which is not present in student table we will fill as null, and for the student table the values which is not present in the course table we will fill as null. So here C name would be null for roll number 1, and here name would be null for roll number 4. Now the fifth join is the self join, or we can say that whenever we perform join on the same table, that is called a self join. So consider that there is a table student, and if we want to perform a join on the same student table, we can use the self join. For the self join we would be learning more in the further videos. For now you can understand that whenever we are performing any join operation on the same table, we use the self join. Now the sixth one is the cross join. So in the cross join what happens is, consider that there are 2 tables A and B. So what happens here is, if there is any row in the A table, it will go ahead and do a Cartesian product with all the particular rows present in the B table. Then the second row of the A table would do the Cartesian product with all the rows which is present in the second table, and then the third row will go ahead and do the Cartesian product with all the rows which are present in table B. So what happens in cross join is, now roll number 1 and Ram would form a pair with roll number 2 Hindi, then with roll number 3 English, and then with roll number 4 maths. Then roll number 2 will go ahead and form a pair with roll number 2 Hindi, roll number 3 English, and roll number 4 maths. In the same way, roll number 3 will go ahead and form the pair with roll number 2, roll number 3, and roll number 4. So there is a Cartesian product, or there is a cross join which is happening, that one particular element of a given table is going ahead and doing a cross product with all the elements or all the rows which is present in table B. So that is why it is called as a cross join. And in the cross join, the number of rows in the final table is m into n. So consider that in the student table there are m rows, and in the course table there are n rows. So the final table would be having m into n, that is 3 into 3, 9 rows. So what is inner join? Inner join help us in getting the rows that have matching values in both the tables according to the given join condition. So whenever we want the values which is matching on both the tables, we use the inner join. So consider that there are 2 tables A and B. Whenever we want the values which is present between both the tables, that is this particular value, we use the inner join. Now here you can see that there are 2 tables, customer and order, and here there is one column which is common between both the tables, that is ID. So what we need to find is in both of these tables, customer and order, give me the values which is present in customer as well as order table. So let's see, is 101 present in the order table? No. So for now this is discarded. Then 102, is 102 present in the order table? Yes. So this is the value which would be returned in our final result. Then it will check for 103. Is there any value with the 103 existing in the order table? Yes. So we will be returning 103 as well. So it will give me all the values which is matching between both of these tables. So the query for the same is, we give select, and then we provide all the columns which we want to see the data among both the tables. Then we provide this from, and then here we provide the table 1, that is this particular table, customer table, and then we perform this inner join, and then we provide the table 2 name, that is order, and then we provide on, and then we provide the condition on basis of which we are performing the join. So the condition is table 1 dot column name. So this dot column name basically refers to a column which is present in table 1. So table 1 dot column name should be equal to table 2 dot column name. So basically the column which is similar between both the tables, perform the inner join on that particular table. Now here you can see that at the first I have given the table 1 and in the second I have given the table 2. So can we reverse this order? So for inner join we can reverse the order because ultimately we are focusing more on getting the values which is common between both the tables. So even if table 2 is on the upper side and table 1 is on the lower side, it doesn't affect our result. But when we go to other type of joins, we have to maintain the order in which we want to fetch the data. So let's see from an example. So this is the query which returns the rows where there is a matching ID in both the tables. So what it will do, it will give select and then it will provide star. So it will get all the columns which is present in both of these tables, and then we will provide from, and then we will provide the table 1 name, that is customer, and then we will perform this inner join, and then we'll provide the table 2 name, that is order, and then we'll provide on which particular columns these values needs to be inner joined. So for customer we are using the column as ID, and for order we are using the column as ID. So in both of these tables ID is the similar or a common or a shared column. So on ID we are performing the inner join and we want to see all the details of a particular customer as well as their orders. So whenever we perform this particular query, we will get the result as this. So here you can see that among all the IDs which is present in customer and order table, the ID 102 and 103 are common among both the tables. So we'll get the details for 102 and 103. Then we'll get the name which is present in table 1, and then we'll get the ID which is again present in table 2, and then we'll get the order name, that is fruit. In the similar way we will get for 103 Riti. 103 is the ID which is for the second table, and then the order name as ball. So if we want to eliminate this ID which is being repeated twice, we can provide the column name specifically from which we want to fetch the data. So here we can provide ID name and order name. But if we provide star, it will fetch all the columns which is present in table 1 as well as table 2. So let's see from the MySQL workbench. So here to perform the queries, let's just create an e-commerce database. In that particular database, we would be creating two tables. One is the customer table and the second one is the order table. So I've already written all the queries just to save time. But I'll be executing all the queries just now. So here you can see we are executing this create database e-commerce. So we'll just execute this query. We have got a success. Here if we do a refresh all, we can see a database with the name e-commerce is created, which is right now having no tables. So we'll then tell the MySQL server that we want to create all the tables inside this particular database. So we'll just execute this query, use ecom, and then we will create a table with the name customer, which is having attributes such as ID and name. Then we will fill some data into this particular customer table. So let's just fill the data, and then we will see that if all the data are filled or not. So let's see. So we have provided the details of 5 employees. We have provided their name as well. Now let's create a order. For that, again, we will tell the MySQL server that in this particular database, we want to create the table. So we will execute this use followed by the database name. Then we will create the table for the orders. So here we have got a success. Here if I do a refresh all, so in the tables you can see that we have created two tables. First is the customer and second one is the order. So let's just fill some details in the order table as well. So we'll just execute this query. So this is a success, and then we will check that if all the details are filled in our order table or not. So we'll just execute this query. So here you can see that we have filled the details for 3 of the orders along with their ID. Now we want to perform an inner join on both of the tables. Now both of the tables have a common column between them, that is ID, which is present in the customer table as well as the order table. So let's perform the inner join basis on ID, and then we will try to fetch all the particular details which are there in customer like ID name, and then in order like ID order name, for all the values which are common between both of the tables. So let's just write the query select, and then we will give star, and then we will give from, and then we'll give the table 1 name. For now we can give any of the table, but let's just take the customer table as table 1. And then we will give the inner join, and then we will give the table name on which we want to perform the inner join, that is order, and then we will provide the condition on which we are joining, that is on customer dot ID, which basically tells that in this particular customer table we are fetching the ID column is equal to orders dot ID, because this is the shared column between customers as well as order. So let's just execute this query. So on executing, you can see that we are getting the details of only 3 of the IDs, that is 2, 3 and 4, which was common among both orders as well as customer. Now we are getting the name, then again we are getting the ID from table 2, and then we are getting the order name. If it doesn't want to see this replicated column, so let's just give the query here as customer dot ID. So this will give me the customer ID. This particular dot is basically used to refer to a column which is present in this particular table. Then we will give orders dot order name, and then we will give this customer dot name. So what this will do is this will give me the ID from customer table, name from customer table, and order name from the orders table. So let's just execute this query. So here you can see that we have removed that replicated column that was ID. So here you can see that you are getting the ID, you are getting the order name, and you are getting the name. So in this way we perform the join. We basically get all the details from both the tables using the common or the shared column between those tables. In inner join we basically focus more on the common values which is present in both of the tables. So left outer join is a part of outer join. Now it is used to fetch all the records from the left table along with the matched records from the right table. So consider that we are having two tables, A and B, and A is the left table and B is the right table. So in the left outer join we get all the details of the left table along with the values which is common between A and B table. So we get all the records from the left table along with the matched records from the right table. So we get this entire detail using the left outer join. Now if there are no matching records in the right table, null values are returned for the columns of the right table. So if there is no matching record which is found in the right table, consider that in the left table there are records as 1, 2 and 3, and in the right table there is only 2 and 3. So for the left table it will take all the records 1, 2 and 3, but there is no one which is present in the right table. So for that the values for the right table will be filled as null, or the columns which is present in the right table will be filled as null. So here you can see the query. So we basically give select, and then we provide all the columns which we want to show in the final result, and then we provide from, and then we provide table 1. So here table 1 is the left table. We need to maintain this order because eventually we want all the details of the left table. If we reverse the order, we will get all the details of the right table. So we need to maintain this order. So we'll give from, and then we will give the table 1, and then we will give the left join, and then we will give the table 2. So basically we are performing a left join on table 1, which is taking all the details of table 1, and then the matched details between table 1 and table 2. And then we will provide the condition on which table 1 dot column name is equal to table 2 dot column name. So perform the left outer join on table 1 and table 2 on the basis of the common column which is present between table 1 as well as table 2. So what is the left table? The table specified before the left join keyword is called as the left table, that is table 1, and the table which is specified after the left join keyword, this is the right table. So table 1 is the left table and table 2 is the right table. Now let's see how it is happening. So there are two tables, customer and order. So here customer is the left table and order is the right table. Now in the left outer join, what will happen? It will take all the values of the left table and then the common values between the left as well as right table. So firstly it will take all the values of the left table, that is 101, 102 and 103. So it will take 101, 102 and 103. Then it will find the common values between these two tables. So here is ID 101 present here? No, ID 101 is not present here. So for now, for order table, we will fill the null values for ID 101. Now, is ID 102 present here? So yes, the ID 102 is present here. So we will take the value as 102 and fruit. So we'll take the value as 102 and fruit. Now, is the ID 103 present here? So yes, the ID 103 is present here. So it will take the ID as 103 and the order name as ball. So it will take ID 103 and order name as ball. So for the ID 101, it didn't had any of the entry in the table 2. So it filled null value for all the columns of the table 2. So let's see from the MySQL workbench that how it is happening. So here we performed the inner join. Now let's perform the left outer join. So we will just give select. We'll use the same tables, customer and the order table. So we'll provide select, and then for now let's see all the details. So we will provide star, and then we will provide the table name from customer, and then we will provide the join, like type of join. So we'll give left join, and then we'll provide the right table name. So the right table name here is orders, and then we will provide the condition. So we'll give on customer dot id is equal to orders dot id. So this is the condition on basis of which we are performing the left join. Basically this particular column and this particular column is a shared column and they have the equal values. So let's just execute this query. So here you can see that we are getting the ID as 1, name as Rahul, and here in the ID section for the right column we are getting null and null. So basically the values which were not present in the right column we are getting as null and null. Then for the ID 2 there is a value which is present in right table, so we are getting all the values. For ID 3 there was a value, for ID 4 there was also a value, for ID 5 there was value only in the left table but there was no value in the right table, so it is null and null. And this way left outer join performs. So the right join or right outer join is basically used to fetch all the records from the right table along with the matched records or the common records which is present between the left and the right table. So consider that there are two tables A and B. A is the left table and B is the right table. So in the right outer join we get all the details which is present in the right table along with all the common values or common records which is present between both the tables. So we get all the details of the right table along with the common values which is present between the left as well as the right table. Now if there are no matching records in the left table, null values would be returned for the columns of the left table. So consider in the right table we have IDs as 1, 2 and 3. In the left table we have IDs as 2 and 3. So for the right outer join it will take all the details of the right table, but here you can see that 1 is not present in the left table. So for the left table columns it will fill null values. Now let's see the query. So the query is select, and then we provide the columns which we want to see in our result, and then we provide from, and then we provide the table 1, and then we provide which type of join we are performing, that is right join, and then we give the table 2 name, and then we provide the condition on basis of which we are doing the join, that is table 1 column name should be equal to table 2 column name. So left table is the table which is given before the right join, and the right table is the table which is given after the right join. So table 2 is the right table and table 1 is the left table. So let's understand that how this particular right join is working. So consider that there are two tables, customer and the order table. Order is the right table and customer is the left table. Now in the right outer join, we get all the details of the right table along with the matched values between left and right table. So it will take all the values of the right table, that is 102, 103 and 104. So it will take 102, 103 and 104 along with all the values such as fruit, ball and utensils. So here you can see fruit, ball and utensils. Now it will find the common values between these two tables. So is 102 present here? Yes, it's present, 102 and Rahul. So it will go ahead and fill the details of 102 and Rahul. Is 103 present here? Yes, it's present. So we'll fill the details of 103 and Riti. Is 104 present here? So 104 is not present here, so we'll fill the values as null and null. Now let's see from the MySQL workbench that how it is working. So it works in a similar fashion of left outer join. It's just that we get the details of right table rather than the left table. So I'll give select, and then we will provide star, and then we will provide the first table name, that is the left table name, that is customer, and then we will give the join type, that is right join, and then we will provide the right table name, that is orders, and then we will provide the condition on which we are performing the join. So that is customer dot id is equal to orders dot id. So let's just execute this query. So here you can see that we are getting the ID 234, we are getting the name Apsara, Abhimanyu, Aditya. Now for the left table, we are getting the ID as 234 and we are getting the order name as fruit, ball and utensils. So all the details which were present in the right table were there in the left table. So we are not seeing any of the null values. So it is kind of giving me the common as well as all the values which are present in the right table. So in the earlier videos, we learnt about left join as well as right join. Now what happens in left and right join? So consider that there are two tables. So this is basically a Venn diagram. So there are two tables A and B. A is called as a left table, B is called as a right table. In the right join also, let me just draw a Venn diagram, A and B. A is the left table and B is the right table. Now in the left join, we usually get all the details which is present in the left table as well as the common details which is present between the left as well as the right table. So if I want the details of the left table as well as the common details between left and right table, we use the left join. Now in the right join, basically as the name suggests right, so we get all the details of the right table along with the common details of the left and the right table. So basically when I want the details of the left table along with the common details between left and right table, I use the right join. And when I want the details of the left table along with the common details between left and right table, I use the left join. Now what is full join? So full join basically returns the matching rows of both left as well as the right table and also include all the rows from both the tables even if they don't have a matching rows. So full join basically is a combination of the left join as well as the right join. So in the left join, we get this particular area. In the right join, we get this particular area. So let's name the area as C. So in the left join, we get A plus C. And in the right join, we get B plus C. So basically in the full join, it is a combination of left join as well as right join. So we will get A plus C plus B plus C. Now here I'll get all the details of A, I'll get all the details of B and the common area between them, that is C. But here you can see that C is repeated twice. So C is also occurring in the left join, C is also occurring in the right join. So is it like we will see the details of C twice? So basically that doesn't happen. I'll tell you the reason in a couple of minutes, but we usually get the details of A as well as B as well as C in the full outer join. Now, if there is no match, null values are returned for the column of missing table. So consider in the left table, we have a column called as ID. Now in this ID, we have 1 and 2. In the right table also, we have a column ID, but in this column, we have only 2 and 3. So here you can see that for 1, there is no entry in the right table. So if there is no match which is found, we usually fill the null value. Now how we would achieve the full join in SQL? So basically in the right join, we were using the right join keyword. In left join, we were using the left join keyword. So is it like in the full join, we would be using the full join keyword? Let's understand. So in MySQL, the syntax for a full join is different compared to other SQL databases like PostgreSQL or SQL Server. So in MySQL, MySQL to make a full join, the query is slightly different from other SQL databases. So what is the difference? MySQL basically doesn't support the full join keyword directly. So we use a combination of left join, right join and the union keyword to achieve the result. So basically in MySQL we can't use the full join keyword. So what we do, basically the full join is a combination of left join as well as right join. So we use the union keyword between them. Now the question which would be coming to your mind is, what is union and how it is helping us to achieve full outer join? So union is basically a concept which comes in math, wherein if there are two sets, A and B, and whenever we do a union between A and B, it gives me all the values which is present in A along with all the values which is present in B, and then the values which is present in A as well as B without any duplicates. So it eliminates the duplicates. So this is the answer for the last thing, where we discussed that full join is basically a combination of left join as well as right join. In left join we had A plus C, in right join we had B plus C. So in the final result we were not getting C twice. So the reason behind not getting C or this particular area twice is because we are using union, and union basically give us all the details of A and B, eliminating the duplicates. So full join is basically a combination of left join as well as right join. Now here is the query for the same. So firstly we'll write the query for the left join, and then we'll write the query for the right join, followed by a union between them. That is this. So first we give select, and then we provide the columns which we want to see in the final result. Then we provide from, and then we provide the left table name, followed by this left join keyword, and then we provide the right table name, and then we provide a condition between which we are joining two tables. So table 1 dot column name is equal to table 2 dot column name, and then we provide this union keyword, and then we provide the right join, that is select, followed by the columns, then from, then the left table name, followed by right join, then the right table name, and then the condition on which we are performing the right join. So basically this is left join, union, right join, which will give me full join. So let's see from the MySQL workbench that how this query is working. So here we have created a database ecom. In that particular database we have two tables, customer and orders. So we will be seeing about the full join on these two tables only. So here we have written some query for the left join which we learnt in the last video, as well as the right join. Now for the full join we need to provide a union between the left join query and the right join query. So firstly let's see what all details are present in both the tables. So first, to see the customer table, I'll be running this query select star from customer, which will give me all the details, all the columns which is present in the customer table. So that is ID and name. Now let's see for the orders table. So we'll run the query select star from orders. So here we can see that we have ID and order name. So in the full outer join, what will happen is, first there will be a left join between the customers and the orders table. Then there would be a right join between the customers and the orders table. And then we'll provide a union in between them to perform the full outer join. So let's write the query. So firstly, we will write the query for the left join, that is select, and then the columns. So right now we'll see all the columns. And then we will provide from, and then we'll provide the table name, that is the left table name, and then we'll provide the left join, followed by the right table name, that is orders, and then we will provide the join condition. So on customer dot id is equal to orders dot id. Now we will provide the union symbol. So here we'll provide the union, and then we will write the query for the right join. So we'll give select, and then here we'll provide star to see all the columns which is present in the right table. Then we will provide from, and then the left table name, that is customer, followed by the right join, and then the right table name, that is orders, and then we'll provide the join condition. So we will give on customer dot id is equal to orders dot id. So this should be orders. So this is the final query which we have made. First we have provided the left outer join query, then we have given this union keyword, and then we have provided the right outer join query. So let's just execute this query. So here you can see that we are seeing all the details of the left table as well as the right table and the common thing between them. So you can see that 2, 3 and 4, these were common between left as well as right table. So we are getting all the details, ID, name and order name. For the ones which were not common between the left and right table, that is 1 and 5, for them we are getting ID as null and null, order name as null and null, because they were not present in the orders table. So if there are no matching rows between two tables, it provides the value as null there. So this is the final result we get for the full outer join. Now as the name suggests, cross join. So what we do in join, we basically combine two tables. So we combine two tables. Now what we do in cross? So cross is basically something we can say as a cross product. So whenever we are performing any cross product between two tables, that gives me a cross join, or that is the result of the cross join. Now let's understand what is cross join. So basically in cross join, it combines each row of the first table with the every row of the second table. So consider that the customer table is the first table, the order table is the second table. Now according to definition, each row of the first table is combined with each row of the second table. So firstly, we will get the result as 101 ram with 1 fruit and 2 ball. And then for the second row, again it will combine with each row of the second table. So it will be 102 Rahul with 1 fruit and 102 Rahul with 2 ball. So basically there is a cross product which happens between these two tables. And what we get in the cross join is we get the result of the cross product. So consider that in the customer table, if there are m rows, consider it is 1 and 2, and here also the number of rows are 1 and 2. So for now we are considering variable. So consider that there are m rows in the customer table and n rows in the order table. So the product or the result of the cross join is m cross n. That is, for this particular table it will be 2 cross 2, that is 4. So let's verify. So firstly, first row of the customer table would be cross joined with the first and second row of the order table. So first result would be 101 ram with 1 fruit and again 101 ram with 2 ball. Then for the second row, it would be 102 Rahul with the first row of this table, that is 1 fruit, and then again 102 Rahul with the second row of this particular table, that is 2 ball. So this would be the final result of the cross join. Now here you can see that we are getting 1, 2, 3, 4. So here we are getting 4 rows, and if we do m cross n, then m is the number of rows for the first table and n is the number of rows for the second table. So here 2 cross 2 gives us 4. So basically it results in a new table where the number of rows is equal to the product of number of rows in each table, that is m cross n. Now let's see the query for the same. So here you can see the query. So first what we give is select statement, and then we provide the columns which we want to see in the final result. So here we have provided star, which basically means all. So we want to see all the columns which is present in the first table as well as the second table, because join happens between two tables only. Now then we will give from, and then we will provide the table 1 name, and then we will give this cross join, and then we'll provide the table 2 name. So it will give me a product which would be the cross join between two tables, table 1 and table 2, which would be having number of rows as table 1 rows into table 2 rows, that is m into n. So 2 into 2, that is 4. So this would be the final result of the cross join. Let's see from the MySQL workbench that how cross join happens and if we are able to get this result or not. So let's see how cross join happens in the customer as well as the order table. So firstly, let's see what all details are there in the customer table. So we'll just hit select star from customer, which will give me all the details in the customer table. So there are 5 IDs with the name. So it is having 5 rows. And then let's just execute the order table as well. So here there are 3 IDs. So basically there are 3 rows. So we will get 5 into 3, that is 15 number of rows in the final result. So let's just do a cross join. So for the cross join, let's just use the existing tables which are present here, the customer and the orders table, and then we will see that how the cross join is even happening. So firstly, we'll see all the details of the customer table. So we'll hit the select star from customer, which will basically give me all the details of the customer. So here you can see that there are almost 5 IDs and there are name of that particular IDs. And here you can see that there are 5 rows. So the first table is having 5 rows. Now coming to the second table, that is the orders table, we'll run the query. So here we can see that there are 3 IDs present. So there are 3 rows. So 5 into 3 is 15. That means the final product or the final result we get after the join would be having 15 rows. So let's do the join. So first we will give select, and then we'll provide the columns which we want to show in our final result. So for now we want to see all the columns so that we understand that how the join operation is even happening. And then we will provide from, and then we'll provide the table 1 name, that is customer. And then we will provide this cross join keyword, and then we'll provide the table 2 name, that is orders. So select star, which will give me all the columns. Then I'm providing the table 1 name, that is customer, and then I'm providing cross join, and then I'm providing the table 2 name. So mostly it will have m cross n, that is 5 into 3, 15 number of rows. So let's see from the final result if we are getting 15 rows or not. So I'll just execute this query. So here you can see that we have got a cross join of both of the tables, and let's see that how many rows are there. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the final result is having 15 rows, and here you can see that ID 111 is repeated, 222 is repeated, because it is going and cross joining from the each and every row of the second table. So basically whenever each row of the first table is cross joined with each row of the second table, we get the result. So that is m cross n number of rows, that is 5 into 3, 15. So as the name suggests, join. What is join? Basically, whenever we want to join two tables, we use join. Now, what does this self join means? So whenever we are performing join operation on itself, it is called as self join. Now that may sound confusing, but let's understand it how self join works. So a self join in SQL is a type of join where a table is joined with itself. It is a type of inner join. Now, whenever a table, consider that there is a table A, which is having some data, and the column is ID, name, age. So whenever this particular table A is joined with itself, so again there is a table that is the same table A only with the same columns and same values. So whenever we are joining the first table with itself, it is called as self join. So in this particular join, what will happen? Table A will join with table A only. So there is a self join which will happen. Now the very next question which would come to your mind is ki, why do we even need to join a table from itself only? Why do we even need that? Like join is mostly performed on two tables. So why do we even need to join one table from itself only? So let's see this example. This will make a bit clarity and this will give you the reason why we are joining one table with itself. So here you can see that this is a student table which is having details of the student ID, the name, and this one is the mentor ID. So basically there is a group of student. Now in that particular group of student, there is a mentor for each particular student, and that particular mentor is also a student. So that is also provided the student ID. So here you can see that for the very first row, we have given the student ID as 1 for Ram, and Ram is having no mentor. Now for the second row, the student ID is 2 for Rahul, and Rahul is having a mentor who is having student ID as 1. So where the student ID is 1, it is for Ram. So for Rahul, Ram is the mentor. Now again coming to this third row, here the student ID is 3, the name is Riti, and she is also having a mentor as 1. 1 is Ram. So Ram is the mentor for Riti. Now coming to ID 4, that is Riya, and Riya is having the one who is having student ID as 3 as mentor. So Riti is having student ID as 3, so Riti is the mentor for Riya. So in this cases, for now I have decoded it, but if the table is too large, if there is like very much of data or there is a huge data set, in that case we can't go ahead and decode from the table itself that who is the mentor for which particular student. So in that case, what we do is we self-join two tables, and from the first table we fetch the student name, and from the second table we can fetch the mentor name, and can do it vice versa also. So in this way we can know the student name as well as the mentor name who is assigned to the student, where the student ID is always equal to the mentor ID, because student ID is having all the details which mentor is having. So here you can see that I have drawn a hierarchy chart. So in the hierarchy chart, the very first student is Ram. Now Ram is the mentor for Rahul as well as Riti. So if you see here, Rahul is having Ram as mentor, Riti is also having Ram as mentor. And now for Riya, Riti is the mentor. So here you can see that there is a hierarchy which is formed between the mentors as well as the student. So here the self join plays a picture. Now if we go here, the query for the self join is we give select, and then we provide all the columns which we want to display in the final result. Then we provide from, and then we provide the table name, and then we provide an alias for the table name. So why do we even need to provide an alias? So join is basically performed on two tables. So if we give the same table name before or after join, it can result in error. Here you can see that I am joining A with A only. But if I provide an alternate name for both the table, it won't result in an error and it can give me the result. So that is why we provide an alias which provides an alternate name for the table. So this is an alternate name. It's not like it is creating a new table. It's just an alternate name for the table. So it will provide an alternate name as T1 for the first table, and then we will give join. So whenever we perform self join, it's not like we give a keyword as self join. We only provide the join keyword whenever we are doing the self join. And then we will again provide the table name, and then we will provide an alias for the table name, that is T2. So there will be T1 and T2, which is having almost the similar details only because it is the same table. It's just that we are joining it, so we are making two tables and we are joining the same table with itself only. Then we'll provide the condition. So we have provided the condition on T1.column name equal to T2.column name. So whenever you find T1.column name equal to T2.column name, do a self join. Now here T1 and T2 are aliases for the table used to distinguish between the order of the rows. So basically whenever we want to distinguish between two tables, between their rows or something, we can provide an alias. Now here you can see the query which I have written to find the mentor name as well as the student name. Now here we are providing select, and then here we are providing S1. So what is S1? So S1 is basically an alias which is provided for the student table only. So whenever we provide an alias for any of the table, we can use the columns or access the columns using the dot. So here we are accessing the column of S1, that is the student table only. So S1.name as mentor name. So we are providing an alias for this S1.name, that is the mentor name. So first table would be having the mentor name. And then we are providing s2.name as name. So s2 is again an alias which is provided for the second table. So for the second table, s2.name is referred as name. So we will get a final result where we will get the mentor name and the name. Then we will provide from, and then we will provide the table name, then we'll provide an alias, and then we'll provide an alternate name. And then we'll provide the join keyword for the cell join, and then again we'll provide the table name on which we are joining, and then we'll provide an alternate name for the same table name. And then we will provide the condition. So here the condition is where s1.sid, so basically this one. So whenever s1.sid is equal to s2.mentorID, so whenever s1.sid like 1 is equal to the mentor ID, give me all the rows. So what it will do is it will check if 1 is equal to this, no. If 1 is equal to this, yes, so give me Ram. If 1 is equal to this, yes, give me Ram. If 1 is equal to 3, no, don't give me Riti. So in the same way it will perform for 2, 3 and 4. Now let's see the final result. So here in the final result we get the mentor name as Ram for Riti, the mentor name as Ram for Rahul, and the mentor name as Riti for Riya. Let's verify here. So for Riya, the mentor was Riti, for Riti, the mentor was Ram, for Rahul, the mentor was Ram, and for Ram, there is no mentor. So this is the final result which we get. Now, if you're still getting confusion that how this cell join is even happening, so let me just explain again. So what is join? Join basically combines two tables and gives us the details. Now, in the join, what happens is that there is a cross product, which always happens, and then we provide the condition on that cross product, which gives us the final result. So in join, what happens? We are combining two tables. So whenever we are combining two tables, there is a cross product which happens, and then it eliminates all the pairs based on some condition. So here we have a condition s1.sid is equal to s2.mentorID. So let me just refer it as MID. So let's draw the table which we have. So what we will do whenever we are performing cell join is first we will find the cross product. So to find the cross product, we need to understand that what kind of join this is. So this is a cell join, so it will get joined with itself only. So there is one more table which is having exactly the same details as this table. So this is the mentor ID, and then they are having the same details 3, 4, Ram, Rahul, Riti, Riya, and then it's null 1, 1 and 3. So let's just perform the cross product. So in cross product, what happens is each row of the first table is cross joined or co-joined with each row of the second table. So basically there will be a pair which will be made, which will be having the first row of the S1 and all the rows of S2. So the very first set which we will get is 1 Ram null, which is joined with 1 Ram null, 2 Rahul 1, 3 Riti 1, and 4 Riya 3. Now again for the second row we will do the cross product, so it will get joined with 1, 2, 3 and 4. So the second row is 2 Rahul and 1, which will be joined with 1 Ram null, 2 Rahul 1, 3 Riti 1, 4 Riya 3. Now again for the third row it will be 3 Riti 1, which will be again joined with 1 Ram null, 2 Rahul 1, 3 Riti 1, 4 Riya 3. Now the final one would be 4 Riya 3. So it will be 4 Riya 3 with 1 Ram null, 2 Rahul 1, 3 Riti 1 and 4 Riya 3. So these are the 4 sets which we have got: set A, set B, set C and set D. So here in the cross product we have got 4 sets, which is kind of each row of the first table is cross product with each row of the second table. Now cross product is done. Now we need to apply the condition. So here the condition is s1.sid is equal to s2.mid, that is mentor ID. So s1.sid is this and s2.mid is this. So is 1 equal to null? No, rejected. Is 1 equal to 1? Yes. So this will appear in final result. So this will be the one which will appear in the final result. Now is 1 equal to 1? Yes. So this will also be appeared in the final result. So is 3 equal to 1? No. So we'll just discard this. So from here we have got 1 Ram null, 2 Rahul 1, 1 Ram null, 3 Riti 1. Now let's come to the second set. So this is the SID and this is the MID. So is 2 equal to null? No. Is 2 equal to 1? No. Is 2 equal to 1? No. Is 2 equal to 3? No. So from set B we have got none of the pair. Now let's go to the set C. So is 3 equal to null? No. Is 3 equal to 1? No. Is 3 equal to 1? No. Is 3 equal to 3? Yes. So basically here 3 is the student ID and here all these fields are the mentor ID. So it is basically the S1 details and it is basically the S2 details. So from here also we have got a set that is 3 Riti 1 along with 4 Riya 3. Now coming to the 4 set. So here is 4 equal to null? No. Is 4 equal to 1? No. Is 4 equal to 1? No. Is 4 equal to 3? No. So from here also we have got no sets. So here you can see that we have got 1, 2 and 3. So we have got 3 rows in the final result, and here also you can see that we have got the 3 rows in the final result. So in the final result we are showing s1.name as the mentor name and s2.name as the name or the student name. Now let's figure it out. So here s1.name is Ram. So the very first mentor name is Ram, who is the mentor of Rahul, and Ram is again the mentor of Riti. Now the third set is 3 Riti 1 with 4 Riya 3. So Riti is the mentor of Riya. So basically we are getting Ram, the mentor of Rahul, Ram, the mentor of Riti, and Riti, the mentor of Riya. Let's go to the final result. So Ram, the mentor of Riti, Ram, the mentor of Rahul, and Riti, the mentor of Riya. So in this way we get to the final result. I know the video is extending too long, but this is a very important concept, and if you understand this, you can solve any of the join problem, and you can understand that why this particular result is coming and how it is coming. So basically whenever you do a cross product with along any condition, you can get the result of the specific join. Now let's go to the MySQL workbench and see how the cell join is happening. So for the cell join, we will be making a school database. Inside that school database, we will be making a student table, and inside the student table, we will be filling all the details of the student ID, the mentor ID, and the name. So let's just create it. So just to save time, I have written all the commands. So firstly, we'll create the database. So we have created the database. Let's just do a refresh all. So here you can see a school database is created. Now I'll tell the SQL server that all the commands needs to be executed in the school database. So we'll use this use school command. So here it is a success. Now we'll create a table student. In the school database, we'll be having student ID, name, and mentor ID. So here it is a success. Let's just do a refresh all. So here you can see in the tables we are getting the student, which is having columns such as student ID, name, and mentor ID. Now let's just insert the data into the student table. So this is success. Now let's just see that if all the data have been inserted correctly or not. So here we have got 1 Ram null, 2 Rahul 1, 3 Riti 1, and 4 Riya 3. Now let's just apply the join. First we will give the select command, and then we will give the column which we want to show. So for now we want to only show the name. So we will give it as name. Now we will give from, and then we'll provide the first table name, that is student. And since we can't perform join on the same table name, we will just use an alias for the first table name, that is S1. And then we will give this join keyword for self join, and then we'll provide the second table name, that is student, and then we will give as S2. And then we will provide the condition. So the condition is where S1 dot SID is equal to S2 dot mentor ID. So wherever you find the student ID is equal to the mentor ID, just do a self join so that we can get the details of the student as well as their mentor. So let's just run only these much query and see that what we are getting. So here you can see that we are getting an error. Why we are getting an error? So here, since we have provided an alternate name for the tables, so we can't just give it as name because it won't know that from which table you are using the name, because name is present in S1 as well as S2. So for now, let's just use S1.name and S2.name. Now let's just execute this query and see. So here we are getting name and name, which is having Ram, Riti, and Rahul, Riti, and Riya. So here we are getting all the mentors name, and here we are getting all the student name. So we just need to modify the query a bit, because here also we are getting the name and here also we are getting the name. So let's just provide an alias for this particular column and for this particular column so that we get the result in a desired format. So let's just name it as S mentor name, and let's just provide an alternate name for this as student name, or you can say name. So let's just execute this query. And now here you can see that we are getting mentor name and the student name. So the student name is Rahul and the mentor for Rahul is Ram. The student name is Riti, the mentor for Riti is Ram. The student name is Riya and the mentor for Riya is Riti. So in this way we can get the final result of the self join, where we can get the details of the mentor as well as the student. The most common example which is used for the self join is for the employee table, where we find that the employee ID remains the same for the manager as well as their employees. So in that case also we can use the self join. Now, as the word suggests, exclusive. So exclusive basically means whenever we are excluding something, and join basically means whenever we are combining two tables. So whenever we are combining two tables, if we are excluding something, that is used in exclusive joins. Now what are these exclusive joins? So exclusive joins are used whenever we want to retrieve data from two tables, excluding the matched rows between these two tables. Now let's go to the outer joins. So in the outer join, I explained about three types of join. First one was left join, second one was right join, and third one was full join. Now what happens in the left join? Consider that if there are two tables A and B, A is the left table, B is the right table. So in the left join, we used to get all the details which is present in A along with the common details which is present between A and B. Similarly, with the right join, if there are two tables, A and B, where A is the left table, B is the right table, we used to get all the details which is present in the right table along with the common rows which is present between right table and the left table. In the full join, we used to get all the details which is present in the left table along with all the details which is present in the right table and the common rows between them. But in the exclusive joins, we basically exclude this area. So we don't get this area, we only want this particular area which is having the details of A, or only this particular area which is having the details of B, or only this area which is having the details of A as well as the details of B. So here also you can see that there are three types of join. The very first one is the left exclusive join, the second is the right exclusive join, and the third is the full exclusive join. So here the left exclusive join is same as the left join. It's just that in the left join we used to get the common or the matched values between A and B, but here we are excluding these values. Again, in the right exclusive join, it is same as the right join, but in the right join we used to get all the details which is present in the right table along with the common details which is present in right as well as left table. But in the right exclusive join, we only get the details which is present in the right table. We exclude the ones which is the matched rows between A as well as B, or left table as well as right table. Now in the full exclusive join, again it is similar with the full outer join, but in full outer join we used to get all the details of left table, all the details of right table along with the details which is matching between left table and right table, but here we are excluding this particular area. So now let's learn about each and every type of join and let's see the query which we are using for these exclusive joins. So the very first one is the left exclusive join. So whenever we retrieve records from the left table, excluding the ones matching in both left as well as right table. So we are retrieving the records from both the table A and B, where A is the left table, B is the right table. So we are getting all the details which is present in the left, but we are excluding the ones which is present in both the tables or ones which is having the matched rows. So consider for now we are performing the left join only. So how we'll perform it? Consider that this customer is the left table and the order is the right table. So in the left join, what happens is, first it will return all the details which is present in the left table, and then it will find any matching values. So consider that join condition customer.id is equal to order.id. So the condition is whenever customer.id is equal to order.id, perform the join operation. So the join table would be having all the values. So the first one would be ID, name, and then it would be ID and order name from the order table. So let's go to the very first row. So since it is a left join, we need to print all the details or all the information or all the rows which is present in the left table. So 101 RAM would be printed. Now it will find that is ID 101 present here? No, ID 101 is not present here. So we will fill null and null for it. Now we will go to ID 102. So is ID 102 present here? Yes, ID 102 is present here. So we'll fill 102 Rahul, and here we'll fill 102 with fruit. Now it will go to ID 103. So is ID 103 present here? Yes, ID 103 is present here. So it will print 103 Riti with 103 ball. So this was the result we used to get in the left join. But in left exclusive join, what happens is we are excluding the ones which are matching between both of these tables. So what are the fields which are matching between both of these tables? That is this 102 and 103. So 102 and 103 are matching between both of these tables. So we have to exclude this and we have to just print this in the final result. So how we can get this particular row? So here you can see that whenever there is no matching row which is present in the right table, we get the value as null, as there is no matching field which is present there. So here what we will do is, first we'll write the query for the left join. So we will write select, and then we'll provide the columns which we want to show in the final result, then we'll provide from, and then we'll provide the left table name, then we will provide left join, and then we'll provide the right table name, then we'll provide the join condition. So table 1 dot column name is equal to table 2 dot column name, and then again we will provide the condition to exclude the matching rows. So the condition to exclude the matching rows can be where table 2 dot id is equal to null or where table 2 dot name is equal to null. So we can provide the condition where table 2 dot column name is null. So whenever we provide is null, it will only return me this row and it will eliminate all the matching rows, because whenever there is a matching row, there wouldn't be any null value. When it would be a null value? Whenever we don't find any matching row. So that is why with the left join query, we write a where condition which help us to remove the matched rows between left table and the right table. Now the second one is the right exclusive join. So whenever we retrieve records from the right table, excluding the ones which is matching both in the left as well as the right table. Now the query for the right exclusive join remains the same as the right join. It's just that we will again put a where condition, and now this time it will be table 1 dot column name is, because in right join we print all the details which is present in the right table and the matching which is present in the left table. So consider for 102, it find the matching data. For 103, it will find the matching data, but for 104, it won't find any matching data. So it will print 104 utensils, null and null. So here table1.id would be null, table1.name would be null. So that is why here we have provided a condition table1.column_name is null. So the query is select, and then we provide columns, then we provide from, and then we provide the left table name, then we provide the right join keyword, then we provide the right table name, then we provide the join condition on table1.column name equal to table2.column name, and then we provide this where clause which will help me to eliminate the matching rows between these two tables. Now in the full exclusive join, whenever we retrieve records from the right table and the left table, excluding the ones matching in both left and right table, we get the full exclusive join. Now in full outer join, what we used to do is we combine the left join as well as the right join query using a union. So why we use union? Because in SQL there is no full outer join or full join. So we use union to combine the details of the left join as well as right join, which will give me a full outer join. And this union also makes sure that the matched rows between the left table and the right table doesn't occur twice. Because there could be a possibility that in the left join we are getting all the details of the left table along with the common row. In the right join we were getting all the details of the right table along with the commons one. So if we are doing a union of left join with right join, this particular area can occur twice. But union makes sure that this particular area doesn't occur twice. So first we'll provide the query for the left exclusive join, then we'll provide a union, and then we'll provide the query for the right exclusive join. So in this way we can get the full exclusive join. So let's see from the MySQL workbench that how this is happening. So we'll just work on the exclusive joins. So let me just write it. Exclusive joins. Now there are 3 exclusive joins. So the first one is left exclusive join. The second one is right exclusive join, and the third one is full exclusive join. So let's see first for the left exclusive join. So the query for the same would be select, and then we'll provide the columns name which we want to see. So for now we want to see all the columns, so we'll provide star, and then we'll provide from, and then we'll provide the left table name, that is customer, and then we'll provide left join, and then we'll provide the right table name, that is orders, and then we'll provide the condition on which we are joining. So on customer.id is equal to orders.id. So this is the query for the left join. So let's see that what this query returns, and then we'll see that how exclusive join is making a difference. So here we are getting all the details of the left table, and for the right table, the details which were not existing is marked as null. And then we are getting the details of the values which are matching between the left table as well as the right table. So wherever ID is matching between left table and right table, we are getting that details as well. And since it was a left join, we are getting all the details which were present in the left table. Now let's just add a condition. So we have to add a condition where table2, that is orders dot ID is null. So it will make sure that give me all the details where orders.id is null. So whenever there is no matching rows, we can see that the ID is coming as null for the orders table. So it will return me the details of that particular person who doesn't have a matching rows in the right table. So let's just execute this query. So here you can see that we are getting only 2 entries where ID is null for the orders or the right table. So basically it excludes all the matching rows which is present in the left as well as the right table. Now for the right join, the query would be select, and then we want to see all the columns, so select star, and then we'll provide from, and then we'll provide the left table name, that is customer, then we'll provide the right join, and then we'll provide the right table name, that is orders, and then we will provide the join condition where customer.id is equal to orders.id. Now this is the query for the right join. So let's see that what all things are returned here, and then we can see the difference between them. So let me just execute this query. So here you can see that we are getting 2, 3, 4, and here all the rows are matching in between both of the tables. So here we are getting 2, 3, 4, and the entry for 2, 3, 4 is also existing in the order table. So whenever we would be running the exclusive join, we won't be getting any data. Here all the IDs are matching in the right table. So let's see for the right exclusive join. So we'll provide a condition where table1 dot column name is null. And just remove this. So let me just execute this query. So as I told that we are not seeing any data because all of the data were matching in the left table. So since left table and right table both had all the common sets which were present in the right table, we are not seeing any data. Now let's just execute full exclusive join. So for full exclusive join, first we will use the left join, and then we'll perform a union between them, and then we'll provide the right join. Just remove this, and let's just execute this query. So here you can see that ultimately we are getting all the details of the left exclusive join only. We didn't got any data. So here we are getting 1, 5, Rahul, Raj, and here the ID is null and the order name is null. So before moving to the union operator, let's just re-revise some older concepts where we were using the union operator. So what happens in the left join? Basically, if there are two tables, A and B, if A is the left table, B is the right table, in left join we used to get all the details which is present in A along with the details which is common between A and B, that is the common details between the left table and the right table. So let's name this area as C. So we used to get A plus C. Now in the right join, if there are two tables A and B where A is the left table and B is the right table, in the right join we used to get all the details which is present in the right table along with the common details which is present between the left and right table. So here it will be B plus C. Now in the full outer join, what used to happen, we used to get all the details which is present in the left table, all the details which is present in the right table along with the common details which is present between the left as well as the right table. So here we used to get A plus B plus C. Now in SQL there is no full outer join keyword. There is a left join keyword, there is a right join keyword, but there is no full outer join keyword. So in that case we use the union operator. So for full outer join, what we did was we combined the left join and right join together using a union between them. So it combines all the result which is present in the left join along with all the results which is present in the right join. So this and this both were combined to get this. But if we perform a union between the left join as well as the right join, so the left join used to give us A plus C and the right join used to give us B plus C. So here we are getting A, here we are getting B, but here you can see that we are getting C twice. So that is what union is helpful for. Union basically gives us all the values, removing the duplicates, or you can say without the duplicates. So whenever we are performing union between any of two queries, it helps us to remove the duplicates or it helps us to eliminate the duplicates. So it will only print C once. So we get the result which we wanted for the full outer join. So union helps us to achieve results or achieve the combination of results between any two or three queries, and it helps us to remove the duplicates. So here if you can see, union operator in SQL is used to combine the result of two or more select queries into a single result set and give unique rows by removing the duplicate rows. So as I said, consider that if there are two queries Q1 and Q2, which are the select queries. So if we perform a union between these two queries, it will help me to give a single data set, and in that single data set there would be no duplicates. So duplicates won't be there. So there are some things which one should keep in mind while using the union operator. So the very first one is each select command within the union must retrieve the same number of columns. So consider that there are two queries Q1 and Q2 and we are performing a union between them. So if we are selecting some columns here to show in the final result, the number of columns which we are putting here should be the same in query 2 as well. So if we are giving one column here, consider select ID, here we should also give one column. The number of columns should always be same between the two select queries on which we are performing the union. Now the second is the data types of the column in corresponding positions across the select statement should match. So consider in this select statement we are selecting ID, and in this select statement also we are selecting ID. So both of the ID should have the same data type. There shouldn't be any mismatch of the data type, like this ID is a varchar or this ID is a int. We can't perform union in that case. So these columns which we are putting here to select or to see the result should always have the same data type. The third one is column should always be listed in the same order across the select statements. So since we have to maintain the data type, you have to always maintain the order, because if the order is not in sync, we may get the inappropriate or a wrong result, or we may get an error. So we have to always make sure that we maintain the order. We have to always make sure that the number of columns we are mentioning in the select queries on which we are performing union should be same, and we have to also make sure the data type of the column should also match with each other on the specific order. Now let's see that how this union operator works. So firstly we will give select, and then we will provide all the columns which we want to see the details, and then we will give from, and then we will provide the table one name, and then we will provide the union, and then we will give select, and then again we will give columns, and then we'll provide from, and then we will give the table 2 name. So basically there are two select queries. This is the first select query S1, this is the second select query S2, and we are performing a union between them, making sure that all the columns in S1 is equivalent to all the columns in S2, all the data types of the column matches from S1 to S2. So we are performing a union which will help me to give a single result set for these two select queries. So consider that this is the table 1 and this is the table 2, and between them we are performing a union. So table 1 is having a column such as ID, table 2 is also having a column ID, it is also holding integer values, and this is also holding integer values for now. So for the first query, if we execute select ID from table 1, so what it will do, it will give me all the IDs which is present in table 1. So it will print 1, so this is the final result. So it will print 1, then it will print 2, and then it will print 3. Now there is a union symbol, so basically all the things which we have got from here, or all the result which we have got from here, needs to be combined with the second select query. So the second select query says that we have to provide the column ID of the table 2. Now let's go to table 2. So here in the table 2 you can see the first row is 2, like the ID is 2, but 2 is already present in the final list, and what union does is union removes the duplicates. So this 2 won't be printed in the final result, it would be discarded because we have applied a union between these two queries. Now coming to the second row 3. So 3 is also printed in the final result and we don't need any duplicated values, so we will be discarding this as well. Now coming to 4. Is 4 present in the final result? No, 4 is not present in the final result, so we can print 4. So this is the result we get after applying union on these two tables. So let's see from the MySQL workbench that how it is happening. So here we already have an econ database, and in that econ database we have a customer table, we have an orders table. So let's just first select and see that what all IDs are present in the customer and the orders table, and then we'll perform the union to see if duplicated values are being removed and if we are getting a combined data set. So let's just first see the ID which is present in the customer table. So we'll give select ID from customer, and let's just execute this query. So here you can see that we are getting the ID details. So it is 1, 2, 3, 4 and 5. So from the customer table, we are getting the IDs as 1, 2, 3, 4 and 5. Let's see the IDs which we are getting from the orders table. So we will write ID and then we will give from, and then we'll provide the table name, that is orders. So let's just execute this query as well. So here you can see that the IDs are 2, 3 and 4. So 2, 3 and 4 is something which is present in customers as well as orders table. So let's see that if we are getting the duplicated value in the final result or a unique value in the final result. So we'll just provide a union between them and we will execute the query. So I just need to remove this. So let's just execute this query. And here you can see that we are getting only the IDs 1, 2, 3, 4 and 5. So we are not getting any duplicates and we are getting the IDs which is present in the customer as well as the orders table. So like the union operator, we have a union all operator in SQL. So let's just understand that how this union all operator helps us. So union all operator in SQL is used to combine the results of 2 or more select queries into a single result set and give all the rows by not removing the duplicate rows. So in union, we used to combine the select queries and remove the duplicates. But in union all, we only combine the query. We don't remove any duplicates. So we don't take into consideration of any duplicates or something. So we just combine the query. But in union, we combine the query as well as we remove the duplicates. Now let's see the query on how we can use the union all operator. So firstly, we'll give select columns from table 1. So this particular query will help me to fetch some columns from the table 1. Then we'll give this union all operator. Then we will give select, then the columns from table 2. Now this particular query will help me to give all the columns which are mentioned here from table 2. And we are performing a union all operator between them. So this query 1 and query 2 will give me a combined result, but there would be duplicates since union all doesn't take care of the duplicates. So let's see from an example. So consider that this is table 1 and this is table 2. And we are performing a union all operator between them. So what will happen? For now, table 1 is having an ID column. Table 2 is also having an ID column. So we can perform a union all operator. So firstly, it will execute the query 1, which is for table 1, and then it will execute the query 2 followed by the union all operator. So firstly, the query for table 1 would be executed. So we want to see all the IDs which is in table 1. So firstly, 1 would be printed, then 2 would be printed, and then 3 would be printed. Then it will go to table 2. So the first ID in table 2 is 2, which is already present in the final result. But as I told that union all operator doesn't take care about if there is something which is present here because it doesn't remove any duplicate. So 2 will again be printed. Then there is 3. 3 is also present in the final result, but it doesn't take care of the duplicates. It just combined the results which is present in table 1 and table 2. So 3 will also be printed, and then there is 4 in table 2. So 4 will also be printed. So we print the data which is present in table 1 column as well as the data which is present in table 2 column without even considering of removing the duplicates. So duplicates can be there. So let's see from the MySQL workbench that how this union all operator is working. So here we already have the query for the union. So let's just copy the same and we will replace union with union all. And let's see that what we are getting in the final result. So here you can see that we are getting 1, 2, 3, 4, 5 and 2, 3, 4 is again coming even if it's like duplicated, but since we are using union all, in union all we can see the duplicate values. So what is this SQL subquery, inner query or nested query? So SQL subquery is a query which is nested within another SQL statement. So consider that there is a SQL statement Q1 and inside this Q1 there is one more query Q2 that is acting as an inner query. We call this particular query as subquery, which is helping me to perform operations on Q1 based on the data which we are receiving from Q2. So whenever we want to retrieve data based on the result of another query, we use the nested queries. So consider that Q2 give me a result R2 and based on R2 we are doing some filtration on Q1. So it is helping me as a subquery and it is helping me to give the details. Now why do we even need the subqueries? So consider that you are working in a company XYZ. Now companies told you that the average salary which we give to our employee is 1200. Now consider the next year company hire more 50 employees, right? So the average salary can either increase or decrease as well. Now, do we need to calculate the average salary each and every year whenever a new employee is onboarded or whenever a set of employees is onboarded? We don't need to do that, right? So what we will do is we will write a query to find the average salary, and then we can tell you can use this particular query anywhere where you want to find all the employees who is earning more than average salary, where you need to find all the employees name, employee details. You can use that particular subquery everywhere, because that will give me the dynamic value or the value which is at present. It will give me the dynamic value. It won't take the value as 1200 as static value. It will give me the dynamic value. Whenever a new employee is onboarded, the value would be updated. So in the same way, we use the subquery because it helps me to get the dynamic value and it helps to update the data at the real time. So we don't need to update our query each and every time. We write a self-sufficient query like select average salary from XYZ. So what it will make sure is that whenever there is new employee which is added in our database, it will update the salary accordingly. The average salary, consider if earlier it was 1200, now it can be 1250. So it will be updated accordingly. Now here you can see a block diagram where I have given an outer query, and inside this there is an inner query. So this inner query is Q2, this outer query is Q1. The result which we are getting from Q2 is R2, and based on R2 we are performing some logic in Q1. So in this way the nested query works. Now, how we can use the subqueries? So subquery can be used in multiple ways. The very first way is subqueries can be used with clauses such as select, insert, update or delete to perform complex data retrieval. Now here you can see that we can use it with the clauses such as select, insert, update or delete. So let's see that how we can use. So here we have written the query. So we give select and then we provide columns, and here we can provide a subquery which will help me to find another column in which there would be some manipulation which would be already done in the subquery and which I can show in the final result. And then I can give from, and then I have to provide the table name from which we are fetching the data. Now let's see the another way in which we can use the subqueries. So subqueries can be used with where clause to filter data based on the condition. So we can use the where clause and we can filter the data based on some condition. So let's see the query. So here you can see we are giving select, and here star basically means all. So it will give me all the columns which is present in the table. Then we will give from, and then we'll provide the table name. Then we'll give the where clause. And here we provide the column name on which we are doing the manipulations or the filtration. Then we provide the operator like greater than, less than, equal to, in operator or other operators. And then we give the subquery. So this is the query 2 which gives me some result. And based on this result, we are performing some operation. So we'll see the example one by one for each of these ways. But for now, I'm just explaining that how we are using this in each way. Now the third way is subqueries can be also used in the from clause. So we can also use subquery inside the from clause. So let's see. So let's see the query. So here we are giving select, and here we are giving star, which basically selects all the column. Then we are providing from, and inside this from we are using the subquery, and then we are providing an alternate name for the result we are getting from the subquery as alternate name. So let's see from examples that how we can use the subqueries inside the select, from and where clauses. Now let's understand from example how we can use the subqueries using the where clause. So the very first problem statement is find all the employees who have salary greater than the minimum salary. So we have to find all the employees who is having salary which is greater than the minimum salary which is present in our table. So we have to break the problem into two steps. First is we have to find the minimum salary, and then we have to find all the employees who is having salary greater than the minimum salary. So let's see first at how we can find the minimum salary. So first we'll give select, and then we'll give an aggregate function minimum which will take all the values which is present inside the column and will return the minimum value. So we'll give the column name as salary, and then we'll give from, and then we'll provide the table name, that is employee. So this will give me one result, that would be the minimum salary among all the employees. Now the second query is to find all the employees having salary greater than the minimum salary. So this we have already calculated. Now we have to find all the employees who is having salary greater than the minimum salary. So we'll give the query select, and then we want to show the employee name as well. So we'll give name, and then we'll give salary, and then we'll provide from, and then we'll give employee, and then we'll give the where condition where the salary which is given here is greater than the subquery which is this minimum salary. So here we can replace the subquery with the query which we have written here, and we can get the salary which is greater than the minimum salary, or you can say R2. So in this way we can find all the employees who is having salary greater than the minimum salary. So let's see from the MySQL workbench. So we have to find all the employees who is having salary greater than minimum salary. So we already have a company database, and in that we have an employee table. So let's first see that what all details are there in the employee table. So here you can see we have ID, name, age, department, city, and employee salary. So let's just find the employee salary which is greater than minimum salary. So firstly we'll find the minimum salary. So for that we'll give select, and then we'll give the aggregate function min, and then we'll provide the column name, that is salary, and then we'll give the table name, that is from employee. So let's just execute this query and see that what it is giving. So it is giving me 1600, which is the minimum salary among all the salaries which is present in the table. Now let's find all the employees who is having salary greater than the minimum salary. So what we'll do is we'll give select, and then we want to show the employee name and then the salary column, and then we'll give the table name, that is from employee, and then we'll give the where clause, and we'll give the condition where salary is greater than, and here we will replace it with this subquery. So here we are getting the minimum salary as 1600, and here we'll replace it with this, and we'll just execute this. So here you can see that we are getting the name and the salary. So is 2000 greater than 1600? Yes. Is 2500 greater than 1600? Yes. Is 2400 greater than 1600? Yes. So we are getting all the employees' name along with their salary who is having salary greater than the minimum salary. So let's see another example. Find all the employees who is having the minimum age. So we have to find the employees who is having the minimum age. So first what we will do is we will find the minimum age which is present in our table, and then we will compare that. Consider that if the minimum age is 18, is the employee having the age as 18? Is the employee having the age as 18? Is the employee having the age as 18? In the same we will see for all the rows, and we will show the details of employee who is having age as the minimum age. So firstly we will break the problem. So first we'll find the minimum age, and secondly we'll find the employee who is having the minimum age. So how we can find that? So first we need to find the minimum age. So to find the minimum age, we can give the query select min age from employee. So this will give me a minimum age, consider R2. Now I have to find all the employees who is having the minimum age. So I'll give the query select name, and I want to see the age as well. So age from employee, and here in the subquery I'll give where age is equal to the subquery. So it will be replaced by this query because this is giving me the minimum age. So it is giving me the result as R2. So it will be basically R2, and this subquery would be replaced by this. In this way we can find all the employees who is having age as minimum age. So let's see from the MySQL workbench. So we have to find all the employees who is having their age as minimum age. So firstly we will find the minimum age. So to find the minimum age, we'll give the query as select min, and we'll give age, and then we'll give the table name from employee. So let's just execute this query. So here you can see that we are getting the minimum age as 24. Now let's find all the employees who is having age as 24. So we will then calculate all the employees who is having age as minimum age. So we'll give the query as select name of the employee, age from table name is employee, and then we'll give the condition where age is equal to minimum age, and basically this query is helping me to find the minimum age. So I can replace the minimum age with this. So we'll give this, and we'll just execute this query. So there is only one employee who is having age as the minimum age. If there were 2 or 3 employees who were having the age as 24, that data would also be shown here. So let's understand from example of using subqueries in the from clause. So the first question is find the employees who is having age greater than minimum age. So earlier we were using the where clause, but here we will be using the subquery inside the from clause. So firstly we'll find the minimum age, and then we'll find all the employees who is having age greater than minimum age. So let's see how we can do that. So to find the minimum age, the query is select minimum age, and here we are providing an alias or an alternate name for the same, that is min age, and then we'll give from, and then we'll give the table name as employees. So in the second step, we have to find the employee which is having age greater as minimum age. So we'll give select, and then here we have used emp.name. So emp is basically a short name we have provided to this employee table, and we can use dot to select all the columns which is present here. So we can use emp.name, and then we can give from employee emp, and here we can replace it with the subquery, that is the minimum age. So we'll replace this subquery with this, and we can give it as subquery, and here we'll give where emp.age. So basically emp is the short name, so employee.age is greater than what we are getting from subquery, so subquery.minage. So here we are having minimum age, so we'll use subquery.minage, and here we are having age as the column, so we'll be using age. So from here we'll get the result as minimum age, and with a result consider R2, and here we'll use the result which we got from this query to do a filtration. So let's see from the MySQL workbench. So first we'll calculate the minimum age. So we can use the query as select minimum, and we can give it as age, and then we can provide an alias to use that particular result somewhere else also. So we'll give as, and then let's provide it a name as min age, and then we have to give the table name, so from employee. So let's just execute this query and see what it is giving us. So here you can see that we are getting a minimum age as 24. So here you can see that it is replaced by the alternate name which we have given, else it would show min age. So we have replaced it with an alternate name, that is minimum age. So let's find all the employees who is having age greater than the minimum age. So firstly we will use select, and then we'll give what we want to select. So firstly we want to show the name and the age, and then we'll use from, and then we'll give the table name, that is employee. So for now we are giving a short name for the employee table so that we don't have any confusion. So here we'll give a short name for employee, that is EMP. Since we have provided a short name, we have to access the columns such as emp.name and emp.age. And then here I'll replace the minimum age from this subquery. So since I am also using this particular result in my from, so I have to use the subquery also. So I'll just use the subquery, which will help me to find the minimum age. So I can also provide an alias for this as min age query. So I've selected emp.name, that is employee name, emp.age, that is employee age, from employee table, and here I've provided a short name for it. And we are also selecting minimum age. So we are giving from employee table as well as this particular table. And then I'll give the where condition. So where emp.age is greater than this min query dot minimum age query dot min age. So let me just explain this. So this particular would give me a result where there would be a minimum age, and it would be the value which is the minimum among all the employees. Now this particular query, select emp.name will select the name, emp.age will select the name from the employee table only, because emp is the short name we have given to the employee table. And then we also want to make query in this particular table. So we'll give a comma and we'll give the query which will give me the minimum age of the employee, and I'll give an alias for this so that we don't have any confusion. So we'll provide an alias as minimum age query. Now we have given the condition where emp.age, so basically this table, in this table find all the age and see the other table, like this particular query give me a table with the name min age, which is having one value. So check if employee.age is greater than minimum age query dot min age. So from this select the min age and check that if the employee age is greater than min age or not. So let's just execute this query. So here you can see that we are getting the name and age of all the employees who is having age greater than the minimum age. So the minimum age was 24. So everyone you can see is 25, 26, 27, 25. So all are having age greater than the minimum age. So let's understand from an example of using subqueries in the select statement. So we have to print the employees with average age and the age of all the employees. So we have to print the average age and age of all the employees. So basically in the final result we'll be getting something like this, where this would be replaced by the average age of this particular age column, consider it's 23, and here we have to give all the age of employees like 24, 25, and here it will be only 23. To compare that, if the age is 25, what is the average age in the entire employee table? So for this we'll again break it into two steps. The first is find the average age, the second is print the employee's age and the average age. So let's see how we can do that. So firstly we'll find the average age, that is select average age, and then we'll provide from, and then we'll provide the table name. So this will give me the average age of employee. Now we have to print the employee age along with the average age. So we'll give select, and then we will replace this subquery here because this is giving me the average age. So we'll give an alias as average age, and then we'll select age, and then we'll give from, and then we'll provide employee. So in this way we can print the average age as well as age for the employee. So firstly we'll find the average age. So for that we'll use select average, and then we can give age, and then we can give the table name from, and then we can give employee. So let's just execute this query. So here you can see that we are getting the average age as 25.4000. So now let's see all the employees who are having age and average age in the result. So we'll give select, then we are selecting age, then for average age we can replace it with this particular query. I know this might sound weird, that why are we even using this? We can just give average age and we can provide an alias. So I'm just explaining that how we can use the select query inside the clauses, and there might be more complex problem where you'll get the gist that why we are even using subqueries and how it is helping us to make the problem simpler. So we'll select age, and then for the average age we'll replace it with this query, and we'll provide an alias for it as average age, and then we'll give from, and then we'll give the table name as employee. So let me just execute this query. So here we are getting age, and here we are getting average age of all the employees. So with the age we are getting the average age, which is for the entire table. So in this way the SQL subquery works. You will see more complex problem where we are using this subquery concept, and it will help to break down that particular complex problem into simpler problems. Now, finding the nth highest salary of a person in a given data set, this question is like mostly asked in the interviews. It can be asked in the interviews of Amazon, Google, etc. Like this is the most asked question, and this is like one of the most important question as well. So let's find the steps that how we can find the nth highest salary, and then we'll see the query for the same. So here we have to find the nth highest salary in a given data set. Now n can be either 1, 2, 3 till any natural number n. Now if we are asked to calculate the first highest salary, so that we can do very easily. We can use the command as select and then we can give max aggregate function, and then we can give salary, and then we can provide the table name from consider employee table name. So this will give me the maximum salary or the first highest salary which is present in the employee table. But consider that someone asks you to find the second highest salary. In that case, what you will do, you will just write the same query, select, then max, and then salary, and then you can give from, then the table name employee. Now this query will give you the first maximum salary or the first highest salary, but I want to find the second highest salary. So what I need to do is I need to eliminate the first highest salary, then the most maximum salary will be the second highest salary. So I'll just give a where condition where salary is not equal to. So this particular operator basically means not equal to, and then I can replace it with the first query. So this first query gives me the maximum salary, or you can say the first highest salary. So give me the maximum salary which is not equal to the first highest salary. So this will give me the second highest salary. Now consider you are being asked the third highest salary. So the query will get complex and complex. So we have found a query which can be very helpful to calculate the nth highest salary of a person, and that is a very simple query. You don't need to do this complex operation or make many subqueries. You can use that particular query and that will make your work easy. So let's see the steps to find the nth highest salary. So the step 1 is select the column which you want to show in the final result, that is salary. So you have to first select the column which you want to show in the final result. Now step 2 is order the salary in descending order. So you have to order the entire salary in the descending order. So the first highest appears at the first position, the second highest appears at the second position, the third highest appears at the third position, so that you can get the max at the first. Now step 3 is, now the value of n could be anything 1, 2, 3 till any natural number n. So we have to make the query in such a way so that whatever be the value of n, it can provide the accurate or the correct result. So the step 4 is, so at the end of the query we will provide a limit so that on the data set which we have got after ordering this particular salary in descending order, we can fetch the nth highest one. So first what we have done is we have selected the salary column to show in the final result. Then we have ordered the salary in the descending order. So the first highest comes at the first, the second highest comes at the second, the third highest comes at the third, and then we will use this limit clause which will help me to give the first highest, second highest or third highest. So let's see how we can use this. So firstly, let's discuss about the limit clause. So the limit clause is used to restrict the number of rows returned by a query. So whenever we want to restrict the number of rows which is returned by a query, we use the limit clause. Consider that we only want to see the details of top 3 students in a college or in a school. So we'll use the limit clause there, which will restrict it to only top 3 people. So here we have 2 types of limit. One is the variation of the limit clause. So first is limit and then we give n. So it helps to retrieve a maximum n number of rows from the beginning of the result set. So whenever we provide limit 3, so it will return the 3 rows from the beginning of the final result. Now there is one more, limit mn. So here m basically means the number of rows which we want to skip from the beginning, and n is the number of rows we want to fetch after the skipping. So consider if there are 5 rows, 1, 2, 3, 4, 5. So if I give the value of m as 2 and n as 1, so what it will do, it will skip the 2 rows, so it will not show 1, it will not show 2, and then n is the number of rows which we want to show in the final result, so it will only show 1 row. If the value of n would be 2, it would show 3 and 4 in the final result. If the value of n would be 3, it will show 3, 4 and 5 in the final result. So basically m is the number of rows we are skipping, and n is the number of rows we are showing after the skipped ones. So limit mn helps us to retrieve a specific range of rows where m is the number of rows to skip and n is the number of rows to fetch. So basically it helps to give us a rows in a particular range. So let's see the query for the same. So firstly we'll give select, and then here we'll provide the distinct keyword, because there could be a possibility that there are 2 persons who are having the same salary, 1200 and 1200. So in that case that can give us incorrect result. So we'll provide the distinct keyword which will make sure that we are getting only distinct salary, and among that distinct salary or among that salaries which are unique, we are getting the nth highest salary. So we'll give distinct, and then we'll provide salary, and then we'll give from, and then we'll provide the table name. Then we'll provide the order by clause which will make sure to order all the salaries in the descending order. So we'll give the first highest salary in the first, second highest salary in the second, third highest salary in the third, and like this. Then we'll provide the limit clause, and then here we'll provide m and n. Basically m is the number of rows which needs to be skipped from the beginning, and n is the number of rows which we want to show after being skipped. So here the value of m is n minus 1 and the value of n is 1. So the value of n is 1 because we always want to get only one result or only the nth highest salary. So the value of n would always be 1. The value of m is n minus 1 because consider that we want to find the first highest salary. So in the first highest salary, we don't need to skip any of the rows. So here if we give 1, 1 minus 1 is 0. So in that case, we are not skipping any row and we are giving the first highest salary. Consider the value of n is 2. So here if we see m, that is n minus 1, so it will be 2 minus 1, that is 1. So it will skip the first row, and then the value of n is 1, so it will give me the second row, that is the second highest salary. So let's see from the MySQL workbench that how we can find the nth highest salary. So let's find the fourth highest salary. So we'll find the fourth highest salary. So for that we'll write the query as select, and then we'll give distinct, and then we'll give salary, and then we will provide the table name, that is from, and then we'll provide employee, and then we'll provide this order by clause to order them, then the column which we want to order, that is salary, and then the manner in which we want to order, that is descending. So firstly let's see that what is the result of this, and then we will calculate the nth highest or the fourth highest salary. So let me just execute this. So here you can see that we are getting the salary as 2500, 2400, 2000 and 1500. So we are getting all the distinct salary, there is no duplicates, and we are getting the salary in the descending order. Now let's just calculate the fourth highest salary. So we will give limit. So first is n minus 1. So 4 minus 1 is 3, and then n is 1. So we'll give 1, and we will just execute this query. So here you can see that we are getting the fourth highest salary as 1500. So in this way we can calculate the nth highest salary. You can replace the number n with any of the natural number you are being asked to, and this is the most simple query which you can use and get the result. Now as the word suggests, stored procedure. So whenever we are storing some kind of a query in a procedure, we call it a stored procedure. So let's see, these are the programs that can perform specific tasks based on the stored query. So you might have heard about functions in programming. So how these functions were useful? Consider that if we want to find minimum age of a person, we used to create a function, give the function name, and write all the logic inside that function, and wherever in our code we require to find the minimum age, we can reuse this particular function. In the same way, we create a stored procedure, we give that stored procedure a name, and then inside that we write a query, and wherever we want to use that query, we can use this procedure name. So it is basically a collection of pre-written SQL statements grouped together under a specific name. So procedures can be created in two types. One is when we are passing some params in the procedure, and one when we are not passing any params in the procedure, that is parameters are empty. So let's see the query and how we can create a procedure. So we give create, and then we give the procedure keyword, then we provide the procedure name, and if there are any params we can provide, else we can leave it empty. Then we give this begin, which tells that now the query is beginning, and then we provide the query, and then we provide this end, which basically tells now the query has ended. Now the procedure with the name procedure name is created. Now whenever we need to call this, we can use this particular query, that is call, and then we give the procedure name, and then we terminate it. So basically call can be used to call the procedure, and create procedure can be used to create a procedure. So let's see an example where we are using a stored procedure without params. So here we are trying to create a procedure where we get all the order details. So we'll give create, and then we'll give procedure, and then we'll give the procedure name. If there are any params, we'll provide, but since it is without params, so we'll leave it as empty. Then we'll give begin, and then we'll provide the query, that is select star from orders, which will give me the entire order details. And then we'll provide end. And then to call the procedure, we will use this call, and then we'll provide the procedure name followed by the termination. So in this way, we can call the procedure, and in this way, we can create a procedure. So let's see from the MySQL workbench. So first we will create a procedure to get all order details. So let's create. So we'll give create procedure, and then we'll give the procedure name get order details. And since there are no params, we'll leave it as it is. Then we'll give begin to tell the query is beginning. Then we'll provide the query, that is select star from orders, and then we will give this end to tell the query has ended. Now here you can see that we are getting some errors. So what could be the reason behind it? So if you remember that whenever we write any SQL query, if we want to terminate the query, we give this particular symbol. Now here what it is happening is we have provided the query and we have terminated it here only. So it is treating this particular thing as a query. So this begin is not able to find end because it has been terminated here only. So what we do in this case is we provide a delimiter. So what delimiter does is whenever we provide delimiter with any symbol, it considers that symbols as a form of termination, and it will not consider this particular symbol as a termination. So that will remove my error. So let's use this delimiter, delimiter, and then we'll provide a symbol as a delimiter. For now I have provided this symbol as a delimiter. So here you can see that the error has gone, but since I have provided this symbol as delimiter, it will not consider here also termination, it will not consider here also termination. So what I'll do is I'll just remove this termination here, and I'll just provide this delimiter. So for now it is treating this entire query as a single query. Now since we have changed the delimiter, there could be a possibility that in the further queries we have to provide this only. So we'll just change the delimiter back to normal once the query is Done. So we'll just give this as the delimiter. So now the delimiter is changed as back to normal. So let's just execute this query. So here you can see that we have got a success. Now we want to see that if that particular procedure is created and what all details we are getting. So we'll just use call and then we'll give the procedure name. And if there are any params, we'll provide, else we'll leave this as empty. So let's just call this. So here you can see that I am getting the ID and the order name. Basically all the details which were present in the order table I am getting here. So in this way we can create a procedure and in this way we can call the procedure. So let's see another example where we want to return the details of order by ID. Now this is an example of stored procedure with params. So the query for the same is we give create, then we give procedure, then we provide the procedure name, and then we give the column name, and then we provide the data type. Now we give begin, then we provide the query select star from orders where ID is equal to the ID which is provided here. And then we provide this end keyword. And to call this, we basically use this call, and then we provide the procedure name, and then we provide the ID for which we are searching. So what is views in SQL? A view is a virtual table in SQL. So consider that there is an employee table. Now this employee table is having details such as employee ID, employee password, employee name, employee address. Now there are some people of the company who is making ID card for each and every employee. So should we give the access to that particular people to access this employee table? Because this is also having employee password. So this is a data breach, right? So we can't provide the access for this employee table to the people who are creating the ID card. So in this case, what we do is we give a view of this particular table. So in this view, we provide ID and name along with address, which is needed to create the ID card. But password is something which is not needed to create the ID card, and also it is a secure data. So we can't provide access or authorization for this particular table. What we do is we create a view, and the people who are creating ID card can now use this particular table. It is a virtual table, so can use this particular table to fetch the information and create the ID card. So it helps in providing a filtered view of data for security purpose. So let's see how we can create a view. So we give this create, and then we give view, then we provide the view name, and then we provide an alias, and here we provide all the columns from the base table which we want to show in the view. So it basically specifies the columns which should be included in the view. So it helps in data abstraction, security, and simplifying the complex queries. So if we are having a view table, if we don't need some of the columns, so we can just have a view table and we can do any kind of manipulation on that particular view table. It is also helping in data abstraction because it is hiding the password from the ID people, and it is also helping in the security purpose. So since view is just like a virtual table, so all the things which we perform on table can be performed on views. So to see all the data in the view, we give select star from view name. And to delete the view, we give drop view, and then we check that if this exists or not, and then we provide the view name. So all the things which we are performing on a table, we can perform on the views also. So let's see from the MySQL workbench that how we can create a view and how it can be used. So let's just create a view. So we'll create view and we'll give the name as employee view, and then we'll provide an alias. So we'll provide as, and then we'll give the details which we want to show in the view table. So first is ID, second is name, and third is city, and then we'll give from, and then we'll give the table name, that is employee. So here you can see we are getting a success. Now the view is created. Now on this employee view, we can perform any operation. So consider that I want to see the details of employee ID. So I'll use this employee view table. So I'll give select ID, and then I'll use from, and then I'll use this table name, that is employee view. So let me just execute this query. So here you can see that I'm getting the ID details. So view has basically reduced the size of my table, and also it has only the valid details which is needed for the ID card department to create that ID card. Now what is this case and if used for? So whenever we want to perform any conditional logic in our queries, and on basis of that we want some values, we use this case and if statement. So let's see. So case allows you to perform conditional logic within a query. So whenever we want to perform a conditional logic in our query, we use this case. Now it can be used with both select as well as update statement to evaluate the condition and return the specific values based on those conditions. So if there is a condition C1, it will return the value R1. If there is a condition C2, it will return the value R2. So based on some specific condition, if we are getting some specific result, we use the case in SQL. Now consider on the basis of day number, you have to print the day. If the day number is 1, you have to print Monday. If day number is 2, you have to print Tuesday, and so on. So how you can use the case statement here? So let's go to the query. So we'll give case and then we provide this when, and then we provide the condition. So here we can give the condition as day number is equal to 1, and then we provide this then, and then we provide the results. So when day number is 1, we provide it as Monday. Now coming to next statement, so we will give when, and then the condition 2 is day number is equal to 2, and then the result is Tuesday. So in this manner we can provide for all the days. But consider if someone provides the day number as 9. So this is an invalid case because we have only 7 days. So we can provide it in else statement, that else if none of the day number matches, then we can provide the result as invalid. So we can provide the invalid here, and then we can end our case. So it just acts like a switch statement which is present in our programming. So we can use the case like that. Now case can be used with select as well as update statement. So let's see the use cases. So the very first question is categorize the student on the basis of percentage to top, pass and fail in a new column category. So you have been provided with a student percent, and then you have to categorize this percentage on the basis of top, pass and fail. So consider if a student achieves a percentage greater than 90, it lies in the top. If the percentage is between 89 to 34, it lies in the pass. If the percentage is less than 33, then it lies in the fail. So we have to categorize the student. We have to show all these values in a new column called as category. So let's see that how we can do. So we'll give the query as select, and then all the columns which we want to show in the final result, that is student ID, student name and percentage, and then we'll provide the case. So first case is when the percentage is greater than 90, the student will be having top. Second is when the percentage is between 89 to 34, then the category will be pass. And last case is when the student is having less than 33%. So we can provide that in else block. So we can give else, fail, and then we can end this case. But now we want to show all these categories in a new column, or you can say alternate column category. So we'll provide an alias and we will provide here category. So it will show all these results top, pass and fail in the category. So and then we will provide from followed by the table name, that is student. So in this way we write the query for the case when we are using the select statement. Now let's see the use case of case with the update statement. So consider that there are some students who have got some grace marks. Now earlier the student grades were A+, A, B, B+, but now some students have got some grace marks. So update their grades. Where it's A, update it to A+, and wherever it's B, update it to A. So we have to update the grade of the student. Whenever we encounter A, we have to update it to A+. Whenever we encounter B, we have to update it to A because they have got some grace marks. So let's see how we can use case here. So we'll give update followed by the table name, that is student. Then we provide this set, that go ahead and set that particular value. And then we'll provide in which column we want to set the value, that is grade. And then we will provide this particular case. Now when the grade is equal to B, then go ahead and update it to A, and when the grade is equal to A, then go ahead and update it to A+. So this case will give me the values based on if the grade is A or if the grade is B. Go ahead and update it to A+ as well as A, and then we can end the statement. So it will go ahead and update this particular value for this particular column. Whenever we encounter A, it will be updated to A+. Whenever we encounter B, it will be updated to A. So let's see the use case of if. So it is used to return 1, 2 values depending on whether a condition is true or false. It is not supported in many DBs, but it is supported in MySQL. So the query is we provide if, and then we provide the condition, like consider day number equal to 1. Now then we provide the true value, and if this is not true, if this condition is not true, then we provide the false value. So if day number is 1, update or select this particular value. If day number is not 1, go ahead and select or update this particular value. So let's see its use cases. So first is categorize the students on the basis of their percentage to top, pass, fail in a new column category. It's the same question. So here if the percentage is greater than 90, so it is a top student. If the percentage is between 89 to 34, it is a pass student. And if the percentage is less than 33, so it is a fail student. So now we have 3 categories or we have 3 conditions. But using if, we can only provide one condition. On basis of C1, either we can give the result as R1 or R2. But we have 3 conditions here. So how we can use this? So we'll use nested if. So we will use if inside if. And using this we can make the query. So let's see. So first, for these 2 cases we will give it an if, and then we will cover the third case, because if the percentage is greater than 90%, it will not come into this block. But if the percentage is not greater than 90%, it will surely come to this block. So let's see. So first we will give the inner block, where we will give if percentage is between 89 to 34, then give as pass, else give as fail. So if this particular condition is true, provide the value as pass, else provide the value as fail. Now this particular if block will take care of these 2 conditions. Now coming to the final condition, so what we can do it, we will give select SID, name, percentage, all the columns which we want to see in the final result. Then we will provide if, and then we will provide percentage. So if the percentage is greater than 90, go ahead and give the top. If this fails, the percentage is not greater than 90, so it will lie in this particular range, then execute this inner if. So what it will do is, when the percentage is greater than 90, it will go ahead and give the value as top. If the percentage is not greater than 90, then it will go ahead and check in these particular 2 conditions, that it lies in 89 to 34 or if it is less than 33. And here it will check if it lies in 89 to 34, then it is pass. If it does not lies in this as well as this, then this is fail. So in this way we use the if inside if, or you can say nested if. And then we provide as, because we want to show it in a new column category, so it will provide an alternate name, and then it will create a category. And then we can provide from, and then we can provide the table name, that is student. Now you may be thinking that case is very much easier than using if, but if you use the if, the time complexity would be lesser than case. So in if, the time complexity is very less, so the queries run very faster. But when you use the case, the time complexity is a bit more than if, so the queries take time to run. Now let's see the next one, that is if with update statement. So we have to swap all the f and m values, that is change all the f values to m and vice versa. So consider that there is a table where we have updated the wrong male and female. So we have to swap the value of f with m and m values with f with a single update statement and no intermediate temporary tables. So here we need to swap the values. It's kind of updating the value into our table. So let's see the query. So first we'll give update, and then we'll provide the table name, that is employee. So go ahead and update the employee table, and then we'll provide this set the value in the gender column, and the condition is if gender is equal to m, set the value as f, and if the gender is not equal to m, then set the value as m. So this is the true when this particular condition satisfies, this is the false value. So if this particular condition satisfies, then set the value as f. If this particular condition does not satisfy, then set the value as m. So it will go ahead and find if m is there, it will swap with f. If f is there, it will swap with m. So consider if this is the gender column, and in the gender column we have considered 3 rows where it is m, f and m. So first it will go to this row. So it will come here, set gender equal to if gender is equal to m. Is gender equal to m? Yes. So we have to update the value to f. So now it will give me f, this particular conditional statement. So it will go ahead and update the value as f here. Now it will again come to the second row. It will check that if the gender is equal to m. No, the gender is not equal to m, it's equal to f. So it will come to the false value and it will update it to m. So it will go ahead and update it to m. Now again it will come to this particular row and it will see if the gender is equal to m. Yes. So it will go ahead and update it to f. It will give me the result as f. So it would be updated as f. So in this way, this particular if conditional statement works. Now let's start with top SQL interview questions. So the very first question is, we have to write a SQL query first to create a database company, second to create a table employee in it, and third is we have to delete or drop the database. So it's kind of a revision of how we create the database, how we create a table in the database, how we delete the database. So let's see. So first is create a database company. So the command for it is, first we give create, and then we give database, and then we provide the database name, that is company. Now the second is create a table employee inside that particular company database. Now in the SQL server there are multiple databases. Consider this is DB1, this is DB2. So we need to tell the SQL server that I want to create a table in this DB1. So for that we use this particular command use, and then we provide the database name. So it tells the server to create the table inside this particular DB, that is company. Now let's see how we can create the table. So we give create table followed by the table name, and then we provide all the columns which would be present inside our table. So these are the columns name. After the column name, we provide the data type of these particular columns, like employee ID would be holding integer values, first name will be holding varchar, that is character values, last name would be holding varchar, that is character values. Now in the third place, we provide the integrity constraints if there are any. So here we have provided that employee ID is acting as a primary key. Here we haven't provided anything, and here also we haven't provided anything. So we basically provide the column name, the data type, and then the integrity constraint. Now the third is delete the database company. Now we have to delete or remove the database from our SQL server. So what we can do is we provide the command drop, which basically means delete, and then we provide database, and then we provide the database name, that is company. So in this way we can delete the database from our SQL server. Now let's see the next question. So we have to write the SQL query to first create a table employee, second insert data into the table employee, third update the salary for all the people in HR department to 20,000, and fourth delete the data for employee having employee ID as 1, fifth delete the entire table. So there are 5 things which we have to do as part of this question. So let's start with the first. So we have to create a table employee. So again we'll give the command create table followed by the table name, that is employee. Then we'll provide all the columns. So here it is employee ID, employee name, employee department, and employee salary. Then we'll provide the data type. So employee ID will be holding integer values, employee name would be holding string or character values, department will be holding character values, and salary would be holding integer values. Then we provide if there are any integrity constraint. So here we are saying that employee ID is a primary key, which basically means that employee ID will always hold unique as well as non-null values. So this is the way how we create a table. Now the second is we have to insert the data into the table. So we have created a table. Now the next step is we have to insert the data into the table. So let's see how we can insert data into the table employee. So we give the command insert, and then we provide into, and then we provide the table name, that is employee. If you want the data to be inserted in the same order, you don't need to provide the order in which you want the data to be stored. But if there is a different order, like first you want to store employee ID, and then you want to store the value of department followed by name, then you need to provide the order. So this is an optional thing. If you want the entire data set to be stored in this particular manner, you don't need to provide it, but it's better to provide, because eventually we would be knowing that if employee ID is at the first place, so we have to give a integer value. If name is at the second place, we have to give a character value followed by department and salary. So here we provide all the columns in which manner we want our data to be inserted. So the first data would be inserted in employee ID, the second in name, the third in department, and the fourth in salary. So again we provide values to provide the values which we need to insert in these particular columns, and then we provide the value. So now 1 is inserted in employee ID, Riti is inserted in name, IT is inserted in department, and 30,000 is inserted in salary. In the same way we provide for the second value, that is 2, Rahul, HR, and 15,000. So in this way we have inserted values in our table. Now the third is we have to update the salary for all the people in HR department to 20,000. Now we have created a table, we have inserted data into this particular table. Now we need to find a department having the name as HR, and corresponding to this particular department we have to find the salary column, and we have to update the salary everywhere we find the department as HR. So what we do is we provide this update command, and then we provide the table name, and then we give this set. So set basically means go ahead and set this particular value. So it will set the value, and we have to set salary as 20,000, and then we provide the condition that where you want to set the salary as 20,000. So we provide where, and then we provide the column name in which we want to set it, and then we provide it as HR. So update the employee table, set the salary as 20,000 where department is equal to HR. That is what our question was, update salary for all people in HR department to 20,000. Now the fourth is delete the data for employee having employee ID as 1. So we have to delete the data for our employee who is having employee ID as 1. So what we have to do is we have to give this delete command, then we have to provide from, and then we have to provide the table name, that is employee, and then we have to provide the condition like where you want to delete this data. So where employee ID is equal to 1. If you only provide this, it will go ahead and delete the entire set of data which is present in the employee table. But when we provide the condition, it will go ahead and find the employee ID 1 and it will go ahead and delete this particular row from our table. Now the fifth query is we have to delete the entire table. So for deleting the entire table, again we use the drop command. So we use drop table followed by the table name, that is employee. If we want to delete a database, we use drop database followed by the database name. Now consider that you don't want to delete the table, you just want to delete the entire set of data which is present in our table. So for that you can use delete from employee, which I told in the last slide as well, that if you use only this particular command, it will go ahead and delete the entire data set. It won't delete the table, but now your table won't be having any data. Now let's see the next question. So we have to write a query to find the total number of employees working in the IT department. So we have been provided with a table. We have to find the total number of employees who are working in the IT department. From here you can see that we can tell there are 2 employees who are working in IT department. But in real life the database is very huge. So we need to write a query to find the total number of employees who are working in the IT department. Now to find the number of employees or the total, or you can say count, we use an aggregate function, that is count. So count is a SQL aggregate function that returns the total number of rows in a specified table or query. So count, what it does, it counts all the rows which is present in our table. So if I do a count star, it will go ahead and count the entire set of rows which is present in our table. So it will tell me that there are 5 rows which are present in our table. Now it counts all the row regardless of whether they contain null values or not. Even if there are any null values present in one more row which is having only null values, it will go ahead and count that as well. So it's not like it will ignore the null values, it will also count the null values. Now using that count star, we can find the total number of employees who are working in IT department. So let's see. So what we will do is first we will select the table. So we have given select. Now we need to provide count star, which will go ahead and count the number of rows which is present in table. So right now it is 5. So it will count 5, then we give from, and then we provide the table name. So this will give me the result as 5. So right now the count star from employee of this particular table gives me 5 rows. Now we need to find the number of employees who are working in only IT department. Here it is giving me the count of entire rows which is present in my table, but I only want the rows which is having department as ID. So that I'll provide in the condition where department is equal to IT. So whenever I provide this condition, count star will go and then see that which all department is having IT, and it will just count that. So the count star will then return me 2. So here you can see that if I do just a count star for a given table, it will return all the rows. But if I have a specified condition, consider that I want to know for HR department. So I'll replace this department IT with HR. Consider I want to know for marketing. So I'll just replace it and it will give me the count of all the employees who are working in the HR department, marketing department or IT department. Now the next question is write a query to find all the employees that have their name starting from R. So we have to find all the employees who are present in my table who have their name starting from R. So here we can see that there are 2 people who are having names starting with R, that is Rahul and Raj. But in real life the databases are so huge and there are a lot of set of data which is present. So we oftenly write a query to fetch our given condition. Now here the condition is the name should start from R. So do you remember about that like operator? So like operator help us to return any pattern or any matching values. So like, it is used to search for a specified pattern in a column. If you want a pattern like name starts with R but ends with T. So for these particular type of patterns, we use this like operator. Now like operator is oftenly used with percentage and underscore for searching patterns. So let's see. So here we have to find all the employees who have their name starting with R. So what we will do is first we will select the entire table, then we will give from. Here asterisk means select all the rows, and then we provide the table name, that is employee, then we give where, and then we provide this column name on which column we want to provide this like operator, that is name, and then we provide this like operator, so that is R followed by percentage. Now what this query says is, go ahead in this employee table, fetch all the columns, all the rows, and there is a condition that go to the column name and find the name who is having R as the starting character, but this percentage says that the rest of characters can be anything. Consider if you want to find people who are having RI in their first name, so we'll give RI followed by percentage. So it basically says that RI should be the first or second character and rest of the characters can be anything. So basically it makes a pattern for us, and we have to go in our table and find for this particular pattern where I get RI in the first name, and it will go ahead and search in the entire table. Now let's see some scenarios where we can use the like operator. So consider that I want to find the name which starts with A. So I'll give like A and followed by percentage, which means that after A there could be any set of characters can have any values. Then the next we have to find the name that contains RA inside it. So we have given two characters that should be contained in any name. So at the first there could be any characters, at the last also there could be any characters, but the name should be having RA inside it. So we will give like percent, which makes that there should be n number of characters before RA, then percentage, which says there should be n number of characters after RA, and then we give this RA. Now here I have said that there could be n number of characters, but what if I want only limited set of characters, or what if I only say that my name has only 5 characters, or search for a name who is having only 5 characters and having R at the start or R at the end. So that type of question we can also deal using the like operator. Let's see the next pattern where we have to find the name which starts with A and have exactly 5 characters in the name. So there should be only 5 characters in the name and the name should start with A. We have to find this particular pattern. So for finding this we would be using this underscore, which basically matches the number of pattern. So ampersand says there could be n number of characters, but this underscore says that there should be only one character which is present if I have given an underscore. So I'll just give like A and then I'll provide 4 underscore because it says that the name should start with A and the name should only have 5 characters. So in this way I can find the name. So I guess there is a small typo here. It should be A followed by 4 underscore, which matches the criteria that the name should start with A and have exactly 5 characters. So let's see the next pattern where name has A as the second character. So I have to find the name of all the person or all the employees who have A as the second character in their name. So let's see. So if I just give a underscore, it will consider one character. So I can say underscore A. So it will tell that go ahead and find all the names who is having first character as anything but second character as A, and then there should be n number of character. So it would be like, then followed by underscore for first character, then A for the second character, and percentage for the rest of the characters. So let's see the next question. We have to write a query to find the unique salaries in the employee table. So we have to find all the unique, or you can say distinct salaries in the employee table. For this we would be using the distinct keyword. So distinct keyword is used to retrieve unique records from a table, and we have to find the unique salary. So we'll give select and then we will give distinct followed by the column name on which we want the distinct value, and then we will give from, and then we'll provide the table name. So this will give me distinct salary from this particular salary column. Now the next question is write a query to find the second highest salary in a table. So we know the query to find the first highest salary, that is select max salary, and then we give from, and then we give the table name, that is employee. So here max is an aggregate function which works on a column and gives the maximum value of that particular column or attribute. Now this particular select max salary from employee will give me the maximum salary which is present here. So let's see what is the maximum salary. So that is 2500. But we need to find the second highest salary. Now the second highest salary here is 2400, not 2500. So how we will find the second highest salary? What we can do is, we know the first highest salary from this particular query. So we will again write a query and we'll say where max salary is not equal to 2500, then it will give me 2400. So is it sounding confusing? Don't worry, let's see the query first. So what we will do is, first we'll write select max salary from employee where salary not equal to, and then we have written a subquery. So first this particular subquery would be executed. So what is the subquery? Select max salary from employee. Now what is the max salary here? That is 2500. So this is our query after executing the subquery. Now we have to find the max salary from employee, where salary, this means not equal to. So not equal to 2500. So we have to find the maximum salary here, which salary is not equal to 2500. So let's discard this 2500 from here and let's find the maximum salary. This is 2400 and 2400 is not equal to 2500. So we can say the second highest salary is the one in which we exclude the first highest salary. So in this way we can get the second highest salary. So max gives us the aggregated max value from a column. Now let's see a query to find the nth highest salary in a given table. So we know how to find the first highest salary, we know how to find the second highest salary, but we have to find the nth highest salary, where n can be any natural number, 1, 2, 3, 4, any natural number till n. Now if we want to find the third highest salary, we would be then finding the second highest salary, the first highest salary, and we would be excluding it from the third highest salary. So that is not a suggested way. So that is why we need to make a query where we can only give the value of n and we can get the nth highest salary. Consider if value of n is 5, we can get the fifth highest salary. So for that, what we will do is, first let's discuss about order by and limit clause. So order by clause is basically used to order the column either in descending or ascending order, and limit clause given by m and n, it helps to retrieve a specific range of rows. So if we want a specific range of rows, we use limit m comma n. Now here m is the number of rows which we need to skip from the beginning. So consider if m is given as 2. So we need to skip 2 rows from the beginning, and n is the number of rows we want to fetch after skipping. So after skipping these 2 rows, what are the number of rows which we want to fetch? So consider I want to fetch 3 and 4. So I can give the value of m as 2 and n as 2. So it will skip 2 rows and it will give me 27, 25. Now consider if I give the value of n as 1. So it will only give me 27. So in this way, this m and n works. Now let's see the query. So first what we do is we select the salary. Now here we have provided distinct because we need to find the fifth highest salary, but there could be a possibility that 1200 is twice, 1500 is twice. So we need to find the distinct salary, and among that distinct, or you can say unique salary, we need to find the nth highest salary. Consider first, second or third highest salary. So we have used a distinct for this column salary, so it will distinct the values or it will give me unique values of salary. Then we provide from, and then we provide the table name, sorry it would be employee here. And then we give this order by clause, and then we give the column name on which we want to order the value. So order by basically orders the salary in ascending or descending order. So we need to find the highest. So we will be ordering it in descending order, which basically means order the salary in descending order. So what we will do is first we will get the distinct salary. So let's take the distinct salary. That would be 1500, 2000, 2500, 2400, and again 1500 is repeated twice and we are taking the distinct salary. So these would be the salaries. Now what we have to do is we have order by in descending order. So what we will do is we will order this in descending order. That would be 2500, 2400, 2000 and 1500. Now what we need to do is consider that if I want this particular salary, that is the second highest salary. So for this, if I want to put a limit, what I'll do is I'll skip one row from the starting and then I'll get the first row after skipping. So the value of m would be 1 and n would be 1. Consider if I want the third highest salary, so the value of m would be 2 because I need to skip 2 rows from the beginning, and the value of n would be n. So if you see, the value of m is always n minus 1. So that is 3 minus 1, that is 2. So whatever is the value of n, we are just subtracting 1 from that. So we can say the value of m would be n minus 1, and the value of n, we always want only one row, so that would be 1. So it will be limit n minus 1, that is the value of n, and 1 is the value of n. So in this way we can get the nth highest salary. You can like use this query for any of the highest salary, 6, 7, 8, any of the nth highest salary. Now let's see the next question. We have to write a query to find the top 2 highest salaries from a given table. So we have to only find the top 2 highest salaries. So how we can do that? First we have this salary column, and in the last slide you learned that we can use this order by clause to get the maximum salary at the first. So we'll use the order by clause on this salary column. It will order all the values according to the descending order. Consider 1, 2, 3, and now we need to fetch 1 and 2 from this particular list. So what we can do is we can give select salary, and then we can provide the table name from employee, and then we can order the salary in the descending order, basically the column name and then the order in which we want to order, and then here we can give limit and n. So m is the number of rows which we are skipping, but here we want to find the top 2. So we are skipping nothing. So we can give it 0 or we can just ignore it. And we need the value of n, that after skipping what are the rows which you want. So we want 2 rows. So we can give limit 2. So in this way we can find the top 2 highest salary in a given table. Now let's see the next question. So next question is write a query to calculate the total salary and average salary in a department. So we learnt about aggregate function and how it works on an aggregated set of value. So we can use the aggregate function sum here and average here to find the total salary and the average salary. So sum, if applied on this particular salary column, so it will just calculate 1500 plus 2000 plus 2500 plus 2400 plus 1500, and it will give me the sum or the total salary. And if I do the average, it will just perform an average here and it will give me the average value. So sum and average both will be giving me only one value because it is working on an aggregated set of data. So now here I want to find the department's total salary and average salary, and here you can see that there are multiple departments: IT department, HR department, marketing and finance. So we need to group these particular departments as well. So let's see the query for the same. So what we will do is we will select the department and we need to find the total and average salary. So we'll be giving sum, salary and average salary, and here we are using an alias. So alias is basically an alternate name. So it will just do the total of salary and it will give an alternate column total salary, where we would be having the result of this total salary, consider X, and in the same way it will provide an alternate column in the result and it will give me the average salary. But these columns are not created, it's just an alternate, or you can say a temporary column. So I'll get department, I'll get the average salary, I'll get the total salary, but now I want each department total and each department average. So I'll be using this group by clause. Group by will group all the department accordingly. So it will group IT, HR, finance, marketing into subgroups, and for that particular groups we will get the average salary and we'll get the total salary. Again for finance we'll get the average salary and the total salary. So consider if there is a column order in which we have Kurkure, Dairy Milk and Maggie, and we want to know that what is the total amount of all the sales which has happened for Kurkure, for Maggie and for Dairy Milk. So what we can do is we can group them accordingly and then we can find the total sales and then the average sales for them. So in this way we find the total salary and average salary for a particular department. So the next question is write a query to find the rows where a department has null values. So if we don't provide any value for a department for a particular record, or you can say for a particular data entry, it fills a null value there if we don't provide a not null constraint. So we need to find all the rows where a particular column, or you can say department, has null values. So there is an operator called as isNull which we can use. So we'll give select and then we need to find all the columns. So we'll give star from and then we provide the table name, that is employee. Then we'll provide the condition where the column name, here it is department, and then we provide this is null. So basically what it does, it goes in the department and it finds if there is any null value present here or not. If there is any null value found in any row, it will go ahead and return that particular row in the final result and all the details of that particular row. So let's see the next question. We have to write a query to find the duplicate rows in employee for the given column department. So this is my employee table. In this particular employee table, I have to go to this particular column department and I have to see that which all department is having duplicacy. So here if you see, the department is IT here and here as well. So can we say that there is a duplicacy for department column in these two IDs 1 and 3? Yes, we can say. Now coming to HR, so HR is not getting duplicated anywhere, marketing it's not, finance it's not. But again it's a small table, but there could be a huge table or huge data sets. So for that we have to write a query. Now what we can do here is, first we need to find all the departments according to their group. So we need to find that if there is any duplicacy in IT department, in HR department, in marketing department and in finance department. So we need to find according to the departments if there is any duplication or not. So what we will do is we will apply a group by clause on our department column so that it groups the data accordingly. Now we need to find that if these particular groups are having the count greater than 1. If they are having the count greater than 1, it means that there are some duplicate values which are present. If I say that IT department is having only the count as 1, so IT department is only present one time. If I said if IT department is having the count as 2, so IT department is getting duplicated, and that is what we have to find, the duplicate rows. So wherever count is greater than 1, we can say say that there is a duplicacy. Now how can we find this particular count? So we can use this count star. Now using this count star, it basically counts all the rows which is present in our table. So right now count star for this particular table can give me the value as 5, but I only want the count for the department. So consider if I give a condition where department is equal to IT. So it will only count the rows who are having the department as IT. So if I count, it is 1 and 2. So then the count star will be giving me 2. But here I want for all the groups of department, for IT, HR, marketing and finance. So what I'll do is I'll apply this count star on this particular group, and then I'll check that whenever the group is having the count greater than 1, then we can say that there is a duplicacy. So the query is select. Then we need to select the department on which we are applying the group by. Then we give the count star, and then we provide from, and then the table name, and then we provide the group by clause which will group the department according to HR, marketing, finance and IT. And then we provide a condition having. So having we have used here because we have used the aggregated function. So having count star greater than 1. So we'll just find the count star for each. Consider for HR it's 1, for marketing it's 1, for finance it's 1, and for IT it's 2. The count star is 1, 1, 1 and 2 for them. And now I need to find that wherever count star is greater than 1, there is a duplicacy. So we can say that IT department has a duplicacy. Now if you're not understanding about all these things, I'll really suggest you that go ahead and watch a comprehensive one-shot tutorial which is uploaded on my YouTube channel, so that at least you get clear on these terms, and then you can come to this video to practice some questions. So now let's jump to some theoretical question. So first question is, what is SQL? Now SQL stands for Standard Query Language. It is a standard language which is used for managing and manipulating our databases. So whenever we need to do any manipulation, like any CRUD operations in our database. So what is CRUD operation? CRUD operation is basically creating, reading, updating and deleting. So whenever we need to perform any CRUD operations in our database, we use SQL. Now the second question is, what is the difference between delete and truncate? So delete removes the rows from the table based on a condition, but truncate remove all the rows from a table. So if we want to remove a specific row from a table, we use this delete command, but if we want to remove the entire data set which is present in our table, we use the truncate command. Now delete can be rolled back because it contains all the logs, but truncate can't be rolled back because it doesn't log the individual rows and it can't be rolled back. Now the next question is, what is union and union all? So union combines the result of two queries and remove the duplicate rows. So whenever we perform union between two tables A and B, so it will just remove the duplicate rows which is present, and it will give me this particular data and this particular data. Whereas union all combines the result of two queries and include all duplicates. So if there are two queries A and B, it will give me the result of A, it will give me the result of B, and it will also include the duplicacy which is present between them. So union combine the result of two queries and remove the duplicate rows, whereas union all combines the result of queries and give the duplicate rows as well. Now next question is, what is store procedure? So a store procedure is prepared SQL code that you can save and reuse. So whenever we create a procedure, we can use it anywhere in our SQL queries, so that we don't need to type a same query again and again. Consider if I want to find the max salary of a person in many of the queries. So I'll just create a store procedure and I'll be using that store procedure in number of queries, so that we can save it and we can reuse it as well. Now coming to the next question, what is the difference between char and varchar? So char is used whenever we have a data of fixed length. So if I know that name would only be having 5 characters, like all the names which is inserted in our employee table would be only having 5 characters, then I can use char and I can give 5. But when I know that they should be having a variable length, consider email of a person can be having variable length. Some can have 50 characters in the email, but some can have 100 characters also in the email. So for that use case, we use varchar, which is used when we have data with variable length. So even if I am giving varchar, and consider if I am giving 20, if my email is having 22 characters, it will just extend itself. So it's a dynamic way of storage, and you can say that char is a static way of storage. Now coming to the next question, that is explain the types of joins in SQL. So the very first join is inner join. So what inner join says that if there are two sets A and B, or you can say two table A and B, it returns all the records that have matching values in both the tables. So the matching values lies here. Consider I am naming it as C. So inner join returns me all the matching values which is present in A as well as B. So it will return me C. Now coming to left outer join. So left outer join returns all the records from the left table and the match records from the right table. So it will return all the records which is present in the left table, that is A, and it will return the match records from the left as well as right table, that is C. Now coming to right outer join, so it returns all the records from the right table and the matched records from the left table. So it will return all the records from the right table and then the matched records of the left and right table. So that is B plus C. Now coming to full outer join, so it returns all the records when there is a match either in left or in the right table. So it will return all the records if there is any match between the left or the right table. So it will give me records from this left table, the right table, and then the records which are matching between them, that is A plus B plus C. Now coming to cross join, so it returns the Cartesian product of two tables. So whenever we are performing a cross product between two tables, that is all the elements of table 1 is getting cross product with all the elements of table 2, that is table B, then we say it as cross join. And coming to self join, so self join is a join where a table is joined with itself. So whenever we are performing join between two tables who are having the same data set, we can say that this is a self join. Now coming to next question, what is null in SQL? So null in SQL is basically used whenever we want to encounter or whenever we want to save any null values. So it is used to handle null values in SQL. Now coming to next question, what is a foreign key? So foreign key is a key that helps in establishing a relationship between two tables. So if there are two tables A and B, so foreign key help us to establish relationship between two tables, and foreign key is a key which take reference from the primary key in the base table. So you can say that foreign key help us to establish a relationship, and foreign key also take reference from the primary key in the base table. So it uniquely identifies a row of another table. So foreign key is a key which takes reference from the base table. So it is also called it as referencing table, and the table from which it is taking reference is called as reference table, or you can say base table. And foreign key in a given table can also act as a primary key, can also not act as a primary key. So it is not important for a foreign key to act as a primary key for another table. It just takes references from primary key of table A and it establishes a relationship between two tables. Now what is primary key? So a primary key is a unique identifier, or you can say a unique key which uniquely identifies records, or you can say rows in a given table. So if we have different rows in a given table and if we want a unique identifier that can help me uniquely identify record in a table, so that is a primary key. So we can say a primary key is a unique identifier or key which uniquely identifies all records in a given table or in a given relation. Now there are two constraints for a key to be a primary key, that it should always be unique. So there shouldn't be any duplicate values here, and it should always have not null values. So there couldn't be any null values here. So if we are declaring any attribute as primary key, it should always be unique, it should always be not null, and it should uniquely identify all the records or all the rows in our table. Now the next question is, what is the difference between where and having clause? So where is used to filter records before any groupings are made. So consider if we are grouping anything, if we are grouping the department into IT, HR, and we want to know that for that particular groups, what are the total employees, what is the total salary. So before grouping the data, if we want to filter the data, we use the where clause. But if we are grouping the data and if we want to perform some filter or some condition, we use the having clause. So having clause is used to filter records after groupings are made. Or you can say basically whenever we are using aggregate function like group by, we can use this having clause. So having clause is used after grouping the data and where clause is used before grouping the data, and both are used for filtration, or you can say providing some condition. Now coming to next question, what is views in SQL? So views are a kind of virtual table in SQL. So whenever we are creating a virtual table for security purpose, consider that there is a huge table of employee and I want to create ID card for these particular employees. But do the people who are making ID card needs to know that what is the salary of this particular employee? No. So these are some data which needs to be remained with us only. So we will just provide a view of this particular table who would be having a new table, or you can say a virtual table, which would be only having employee name and employee ID, which would be required by the department who are making ID cards. So we are just hiding some of the details which is unnecessary or which is like secure, which doesn't needs to be known by the department who are making the ID cards. So views are a virtual table in SQL. Now what is default constraint? So whenever we want to provide any default value for a given column, we use this default constraint. So whenever we need to fill a column with default, or you can say fixed values, we use default. Like set the default salary as 0 where age is null. So it should be salary is null. So whenever I'm not entering any value for the salary column, and wherever salary is getting as null, we will set the default value as 0. So salary won't be having any null values. If there is any null values, or if we are not entering data for that particular field, or you can say that particular record, we can set the value as 0 for them. Now next question is, what is an alias command in SQL? So alias are temporary names which are given to a table or column which is just a temporary change. That is, table name does not change in the original database. Consider if I am having a salary column in my employee table which is having some records, and I need to find the total salary of all the employees. So for that we can use an alternate name while calculating the total salary. So we can use sum of salary to calculate this total salary, and then I can use an alias, and then I can provide it as total salary. So if I use this in my final result, I'll be getting only one table which would be having only one column, that is total salary, and it will be having the total salary which I have calculated from here, consider X. So this is just an alternate name. There is no changes to the database, no changes to the table name. It's just an alternate name, or you can say a temporary name which we are giving for any calculation which we are providing in any of our columns or set of columns. Now first we'll start with how we can think on what SQL clause operator function to choose in given scenarios or given condition. So the very first scenario is when we want to have a data retrieval. So whenever you want to retrieve some data from the database, it is oftenly suggested to use the select statement, because select statement is used for retrieving data from one or more tables. So whenever you want to retrieve some attributes or some data from the database, you can use this select statement. Now coming to the second scenario, that is data filtering. So whenever we want some data to be filtered, consider based on some condition or consider based on some of the logic, so we would be using all these. So first is where clause. So where clause is used to filter records based on some specific condition. So whenever there is a table, and in that particular table there are some attributes as well as tuples, and if we want to filter some data based on some condition, we can use this where clause. Now coming to and, or, and not operators. So these operators are oftenly used whenever we want to combine 2 or 3 conditions. Consider that I want the data of all the person whose age is greater than 80 and gender is equal to male. So whenever we want to club 2 conditions or multiple conditions, we use this and or not operator. Now coming to between. So whenever we want to do a search based on some specific range, consider that I want the details of all the employees whose age lies between 18 to 50. So for this particular range, if I want to do a search, I can use the between operator. Now coming to in. So in checks whether a specified value matches any value in the subquery or list. So we have a specified value, and it checks that if that particular value matches in the particular list which is present here or in the subquery which is present here. Now coming to like. So whenever we have any pattern matching problems, consider that we want the employee details whose names start with A. We want the employee details who have A as the second character in their name. So for all those questions, we use this like operator. So it is used for pattern matching. We use it with percent as well as underscore, where underscore represents a single character and percent represent the before or after characters. Now coming to the next scenario, that is aggregation on data. So whenever we want a single value for multiple rows, we use this aggregation. So what are all these aggregations? So first is average. It returns the average value of a numeric column. So if there is a column in a given table, and if we want the average of that particular column, we use this average. Consider if there is a salary column and I want the average salary, it will go ahead and find the average for the entire set of rows which is present here. Now coming to min, it returns the minimum value in a column, like consider minimum salary. Coming to max, it returns the maximum value in a column. So if we want the maximum salary, we can use this. Coming to sum, it returns the total sum of the numeric column. So it goes ahead and add all the records or all the data which is present in this salary table, and it will give me the total sum. Now coming to the count. So count counts the number of non-null values in a specified column. So consider if there is a column salary. Now salary has some values A, B, C and consider one value is null because there is no value. So count will go ahead and count the number of rows, but it excludes the null value. So it will give me the output as 1, 2 and 3. So whenever I am performing count on the salary column, it will give me the output as 3 because it will go ahead and count the number of rows which are having non-null values. Now coming to count star. So count star counts the total number of rows in a table including the rows with null value. So if I am using count star, it will go ahead and count all the rows, like it will include null as well as non-null values. So it will give me 4 as the output. So count will exclude the null values, count star will also include the null values. Now coming to the next scenario, that is grouping and filtering of groups. So whenever we want to do some grouping and whenever we want to do some filtering based on that groups, so we use this group by and having. So what is this group by used for? So whenever we want to group rows that have the same values in a specified columns, we use the group by. So consider here there is salary A, B, C, and consider there is one more salary A. Now here we can see that A and A is repeated twice, like for the salary column there are 2 A's which is present, right? So we can group them in a single group, then we can group B, then we can group C. Like in department we used to group department basis on IT, HR, marketing. So group by is basically used at whenever we want to group some data which is present in some specified column. Now coming to having clause. So having is basically a condition which is applied on the group by clause, or you can say which is always applied to an aggregated data. So where is applied whenever we want to filter data based on some condition when the aggregation hasn't happened. But when the aggregation has happened, we use the having clause for filtering the data. So having clause filter the groups based on some specific condition. So we have formed the groups using the group by clause. Now we want to filter on the basis of some conditions. So we will be using having clause. Now coming to the next scenario of sorting of data. So whenever we want to sort our data in ascending or descending order, we use this order by. So order by sorts the result set by one or more columns. So if there is a column, consider salary, and if there are some salaries present, consider 1 rupees, 2 rupees, 3 rupees, we can sort these salaries based on ascending and descending order using order by. By default the order by uses the ascending order, so if we have to give for descending order, we have to say that the order should be descending, so we have to give it explicitly. Now coming to the next scenario, that is data retrieval from combination of 2 or more tables. So consider that there are 2 tables, student and student course details. Now I want some data from this table as well as this table. So I have to join this table. So that is why join is used. So what happens, we can join these tables to fetch some data from this table as well as this table based on a specific column which is common between them. So there are some joins, inner join, left join, right join, full join, which combine rows from 2 or more tables based on related columns. So based on some related columns, it combines the rows and give me the result. Now coming to the next scenario, that is conditional logic. So in where we were filtering the data based on some condition, but how we can create the condition. So for creating the condition, we use this case and if. So whenever we want to create some condition, we can use this case and if. So case perform conditional logic within a query using when, then, and else, and if returns the value depending on whether a condition is true or false. So if we are using this if, it returns the value based on some condition. So if this condition is true, it will return the first value. If this condition is false, it will return the second value. So this is how we use the if. And case we oftenly use with when and then. So we give when and then we provide the condition and then we give the result. So it is then and the result, and then we end it when it's done. So this is the way we use the case and this is the way we use the if. Let's see that how we can solve SQL question or what is the approach we should follow. So the very first step is understand what the question says. So we need to understand that what the question exactly says, like if the question is asking for some retrieval of data, if it's asking for aggregated result or joining tables or performing some updates or deletes. So we have to go through the question and we have to figure out that what specific condition it needs to be accommodated there. Now coming to step 2, check the data type constraints, primary key, foreign key and the relationship between the tables. So if there are multiple tables, we have to check the foreign key and the relationship between those tables. If there is a single table, or consider if there is a table, we need to check the data type of given columns or attributes, the constraints if there are any present, the primary key which is for that particular table. So we have to check for all those things. Now coming to step 3, we have to use the appropriate SQL clauses and functions. So as discussed in the last set of slides, that if there is any data retrieval, we can use select. If there is any filtering based on some condition, we can use where. If there is any grouping, we can use group by. If we need to do filtering on the groups, we can use having. So in the same way, we need to know what are the appropriate SQL clauses or function we can use here. Now coming to step 4, ensure appropriate indexes on the column in where, join and order by clauses. So whenever we are using this where, join and order by clauses, we have to make sure that we are performing the operations based on the indexed column only. So indexing help us to have the results very fast and it increases the query time. If there is no indexing present, it will go ahead and scan the entire database. So that will take a lot of time, right? So the query increases its time whenever there is no indexing present, but if there is indexing present, the data retrieval is very fast. So these are the questions which we would be discussing. I'll provide the links in the description so you can go ahead and watch out the questions and then go ahead and solve it once. So first question is swap salary, second is duplicate emails, third is employee earning more than their managers, fourth is not boring movies, and fifth is class more than 5 students. So let's start with swap salary. So what is the question? So we have to write a solution to swap all F and M values, that is change all F values to M and vice versa with a single update statement and no intermediate temporary table. So there is a salary table which is given, which is having columns such as ID, name, sex and salary, and what we have to do is we have to change M to F whenever we found M, and we have to change F to M whenever we found F. So we have to basically do a swap for M to F and F to M in this particular salary table. So take 2 minutes and think that how we can approach this question, and then we would be solving this problem. So let's start with solving the problem. So what is given here? It is given that we have to swap these values M with F and F with M. Apart from this, there is one more thing which is given, that we have to do an update, and it would only be a single update. Like there shouldn't be any multiple updates involved. The third given thing is that we don't need or we shouldn't make any temporary tables. So temporary tables is not allowed. So here can you see that we are forming some kind of condition that whenever we are encountering M, swap it with F. Whenever we are encountering F, swap it with M. So here we are forming some small kind of condition. So can we use this if and case here since we are making a condition? Yes, we can use. So how we can use is, we'll use if sex is equal to M, go ahead and update the value as F, and if the sex is not equal to M, go ahead and update the value to M. So would this work? Let's see. So it will come here. Is sex equal to M? Yes. So go ahead and update it to F. So it will go ahead and update it to F. Now coming to this, is sex equal to M? No. So go ahead and update it to M. So it will go ahead and update it to M. Now coming to this, is sex equal to M? Yes. So go ahead and update it to F. So it will go ahead and update it to F. Now coming to the last row, is sex equal to M? No, it's F. So go ahead and update it to M. So it will go ahead and update it to M. So here you can see that it has swapped and updated all the values. So we can use this if for forming the condition, and we have to update this particular table. So we have to form the query in such a way that we have to update this table, that is a salary table. And what we have to do is we have to set the sex based on whatever value this condition is giving me. So in this way we can form the query for this particular question. We are going ahead, we are updating the salary table, we are setting the value of sex based on a condition that if sex is equal to M, set it to F. If it's not equal to M, then go ahead and set it to M. So in this way we can perform this particular query. Let's go ahead and solve it from lead code, and let's see that if the solution is working or not. So here we have to update, and the table name here is salary. So we'll just pick this. So salary, and then we have to set the value in the column sex, where if sex is equal to M, then go ahead and set the value as F. If this condition is false, then set the value as M. So if the sex is M, that is male, then go ahead and set the value to F, that is female. If it's not male, then go ahead and set the value as male. So this is the final query which we have made. So let's just execute this query and see if it's running or not. So it has ran successfully for the test case which was provided here. So let's just submit this solution and we'll see that if it is getting accepted or not. So it has accepted. So this is how we can swap the salary. So coming to the next question, that is duplicate emails. So this is the table, person table, which is having ID as well as email. In the output, we have to provide the email which is duplicated or which has more than one occurrence. So write a solution to report all the duplicate emails. Note that it's guaranteed that the email field is not null. So email field would not have any null values. Now we have to return the result table in any order. So there could be a possibility that there are two emails which have more than one occurrence. So we don't have any order in which we want to return the result. Like if B has 2 occurrence and if A has 3 occurrence, we have to return A first or B first. So there is no ordering logic involved here. We have to just return the email in any order. So you can take a 2-minute pause here and you can think that how we can approach this question. Then we will start solving it. So let's solve it. So what is given? So it's given that we have to find the duplicate email. So that is all the emails who have occurrence more than one time in the given table. Now it is also given that email wouldn't have any null values. And the third thing which is given is we can return the result in any order. So there is no ordering logic involved. Now we have to find the occurrence of email, right? So here you can see that there are some emails which is getting repeated twice. So why not to group the emails? So what we can do is we can group the emails in multiple groups, like according to the same values we can form the group. Like there could be a group of A, there could be a group of B, there could be a group of C, and all these are emails. So why not to create the group of those emails and then go ahead and count the occurrence of that email. So we'll group all the emails and then we will go ahead and count the number of occurrence of that email. So it will go ahead and count the number of rows which is present with the email as A, with the email as B, and with the email as C. So would that work? Yes, that would work. So what we will do is first we'll go ahead and group the emails. So on the basis of values, it will be grouped into 3 or 4 or many subgroups, right? Now after it has been grouped into subgroups, what we will do is we will go ahead and count for an individual email, that what is the occurrence of this email, then what is the occurrence of this email. Based on the groups only we are counting, so we only need to perform this count logic once. So what we will do is first we will group the emails and then we will go ahead and count that how many occurrences of A is present in this particular group, how many occurrences of B is present in this group, how many occurrences of C is present in this group. So what we will do in the query is first we will select email which we have to show in the final result, and then it would be from, and then the table name is person. Then we'll perform a group by on the email, and after grouping the email, I'll give a condition that whenever the count of the email which is present in this aggregated group is greater than 1, go ahead and print that particular email in the final result. So we'll go ahead and count the occurrences of all those emails in this particular group, and it will provide me all the emails who is having count greater than 1. So if A is occurring once, B is occurring twice, and C is occurring thrice, so we would be seeing B and C in the final result. So this is how we can solve this particular question. So let's see from the lead code. So we will be giving the query as select, and then the column name is email. So let me just copy from here, select email, and then we will give the table name, that is from, and the table name is person. So person, it would be from, and then we will give the group by. So it will be group by, and then we'll provide the column name on which we are grouping. So that would be email. So we have formed the email groups. Now from that email group, we have to filter all those emails who are having their count as greater than 1. So this is how we can form the query. So let's just execute this query. Okay, so it is accepted and it has run all the test cases. So let me just submit it. So here also the solution is accepted. So this is how we can find the duplicate emails in a given group of data. So coming to the next question, employees earning more than their managers. So we have to write the solution to find the employees who are earning more than their managers. So there is an employee table which is given, in which we have ID, employee name, employee salary and manager ID. So let me name it as MID. So if you consider a scenario of a company, so every employee would be having some employee ID, like I would be also having some employee ID, my manager would be also having some employee ID, my director will also have some employee ID. So all the employees would be having some ID. So that is mentioned here. All the employees' names are mentioned here. All the employees' salaries are mentioned here. And in this manager ID, we provide the manager ID for this particular employee. So consider if the first employee is Joe, the salary is this and the manager ID is 3. So we'll go ahead and see that which is 3 in this ID column. So that is Sam. So the manager for Joe is Sam. Now coming to 2, that is Henry, the salary is given and the manager ID is 4. So what is 4 in this particular column? That is Max. So we'll give Max here. So Max is the manager of Henry and Sam is the manager of Joe. And coming to Sam and Max, there are no managers because they themselves are manager. So here you can see that this is the way we can figure out that who is the manager for this particular employee, right? Now what we have to do is we have to find the employees who are earning more than their managers. So we know all the employees. Now we know their managers as well from the manager ID. Now we have to find out all the employees who are earning more than their managers. So how we will find it? So just take a 2-minute pause, think on the approach which you can think, and then we'll go ahead and solve this particular problem. So let's start solving. So what we will do is we are given with a table which is having employee ID, employee name, employee salary and manager ID. So here you can see that the manager ID is given like 3, 4, null and null. So right now I don't know that for the employee, consider Joe, who is the manager. Like I'm going ahead and manually writing Sam, but there could be a database which is having like huge set of data. So for that data, I won't be going ahead and manually seeing the name and writing it here, right? And again, I need the manager salary as well. So here I'll be needing Sam salary and here I'll be needing Max salary. So what we will do is we will figure out a way in which this particular manager ID displays me all the manager details, right? So this particular manager ID displays me the manager name, manager salary, manager personal details as well. So what I'll do is I'll perform a join operation here. Now how I'll perform a join operation here? So here you can see that there is a hierarchy which is getting formed, right? So here Joe is having Sam as the manager. Henry is having Max as the manager. And Sam and Henry are the employees. So there is some hierarchy which is getting formed. So for all these type of questions where we can see that there is some hierarchy getting formed and some sort of data is dependent on other set of data, we use the join. And here we will be using the self join. So why we would be using the self join? Because here there is only one table and we have to somehow figure out the manager details from this manager ID itself. So what we will be doing is we will be performing self join, that is we will be joining this table from itself. So that whenever this table gets joined with this table, like itself only, we will get the manager details. So how we will get the manager detail? So consider that there are 2 tables for now, E1 and E2. Although these 2 tables have same set of data, but consider that this is the employee table and this is the manager table. Now I need all the manager details. So what I'll do is I'll join this table with this table, and the condition of join would be that E1 dot manager ID is equal to E2 dot ID. So E2 dot ID is the manager ID which is acting in the manager table. So what we have to do is we have to replace this manager ID which is present in E1, or we have to do a join condition based on a condition where E1 dot manager ID is equal to E2 dot ID. So we can replace 1 with all the details and we can replace 4 with all the details. Like replacing here doesn't mean that we are replacing any data, but we will get all the details. So we'll perform a join operation here so that we can get the manager details, and then we can perform the operation that where E1 dot salary, that is employee salary, is greater than E2 dot salary, that is manager salary. So we'll perform a join operation here. So how we will do it? So we'll give select, and then what we need in the final result is employee name. So we will give E1 dot name, because right now we are performing a self join, and in self join we are performing it on the same table, so we can't give the same table name, right? So we have to provide an alternate name for this particular table. So we are giving E1 dot name, and then we will give from, employee E1, and then we'll give the self join, and then I'll give employee E2, that is right now a manager, and this is the employee table, and then I'll give the condition on which I'm joining, that is E1 dot manager ID is equal to E2 dot ID, so that if E1 dot manager ID is 3 here, so we can go ahead and populate the details for 3, and if E1 dot manager ID is 4 here, so we can go ahead and populate the detail for 4. So 3 is Sam and 4 is Max, so we can populate their details here. Now what we have to do is, the condition is where E1 dot salary, that is employee salary, is greater than E2 dot salary, that is manager salary. So we have to check for employee salary which is greater than manager salary. So we are doing a self join here because there is some kind of hierarchy and relationship formed here. Again we are doing a self join because here we only know the manager ID, but we need to know the manager details, manager salary details, name and everything. So that is why we are self joining, so that we can get the manager detail from the other table. Now here we are naming it as E1 and E2 because we are performing the self join on the same table. We can't give the same name whenever we are performing the self join, so we have given E1 and E2. Now this is how we can perform the self join. If you are getting confused here, I have uploaded a tutorial on self join in my YouTube channel. You can go ahead and have a look, so that all the concepts of the self join is clear. Once you understand the self join, this question is a cakewalk. So let's just solve it from lead code. So what we will do is, first we will select E1 dot name, and then the table is from employee E1, and then we'll perform the join operation with employee E2, and then we will give the condition on E1 dot, let me pick the column name from here, manager ID is equal to E2 dot ID, and then we'll give the condition where E1 dot salary, that is employee salary, is greater than E2 dot salary, that is manager salary. So we'll give the select E1 dot name, we want name, then from this employee table E1, and then we are joining it with the employee table only, so we'll give E1 and E2. Then we will perform a query based on E1 dot manager ID is equal to E2 dot ID, and we have to fetch the salaries where the salary of employee is greater than manager salary. So I guess the table name here is employee, so let me just replace this with employee, and let's just run this query. Okay, so we are getting wrong answer. Okay, so here you can see that we are getting the wrong answer. The reason behind it is, in the output we are getting the table name as name, but expected output is we want the table name as employee. So what we will do is, we will just provide an alias. So we'll provide as employee, so it will give an alternate name to this E1 dot name or name. So let's just run this again. So here you can see that now it has ran successfully. So this is how we can go ahead and check our errors and then modify the query as it is. So here the error was that it wanted the name for the table to be employee, but it was displaying as name. So that is why the error was coming. So this is how we can solve the question of employee earning more than their managers. Now coming to the next question, that is not boring movies. So here we have to write a solution to report the movies with an odd numbered ID and a description that is not boring. So we have to get all the movies who are having odd numbered ID. And then the second thing is, they should be having a description which is not equal to boring. So I want to fetch all the movies who are having the odd number ID and the description is not equal to boring. So return the result table ordered by rating in descending order. After that, we have to return the table ordered by the rating in descending order. So this is what is given in this particular question. So again, take a 2 minutes pause, think that what we can use here and how we can approach this question, and then we will be solving it. So let's solve this question. First, we need to think that how we can find the odd numbered ID. So odd number ID here is 1, 3, and 5. So how we can find this IDs? So whenever we do a modulus of any number with 2, and if it gives me the remainder as 1, we call it a odd number. So here we would be using the inbuilt mod function which is present in SQL, where we can provide the column name on which we want to perform the modulus operation. Then we can give the value that is 2 that we want to perform modulus on 2, and then we can compare that if the remainder is equal to 1 or not. So using this we can get the odd numbered IDs. Now coming to description, so description should not equal to boring. So we should go to this description column and we should check that if the description is not equal to boring, or we can also use this operator that is not equal to. Now coming to the next part, that is we should order the result by rating in descending orders. So let's see that how we can form the query for the same. So we'll give select and then star, because we want all the details which is present in the input table. Then we will give from, and then we'll give cinema, and then we will give the condition where. So the first condition is mod of ID and 2 is equal to 1, and the second condition is and description is not equal to boring. And then we have to order the result, so we'll be using order by, and then we'll give the column name that is rating, and then we'll give the order that is descending. Let's go to the lead code and write this particular query and see if it is a accepting solution or not. So first we will give select, and then we will give star since we want all the results in the output. Then we will giving from, and then the table name, so that is cinema. So let me just copy this cinema, and then we will give the condition where the first condition is mod of ID comma 2 is equal to 1, and the second condition is description. Let me pick it from here only. So description is not equal to, and then the value is boring. So we'll give boring, and then we will order the results. So we'll use order by, and then we'll give the column name that is rating, and then the order that is descending. So let me just run this query. So here you can see that the query is accepted and has run all the test cases. So let me just submit it. So here you can see that the query has been accepted. So this is how we can find the not boring movies. Now coming to the last question, that is classes more than 5 students. So we have to write a solution to find all the classes that has at least 5 students. At least means either greater than or equal to 5. So we have to find all the classes who are having at least greater than or equal to 5 students. So this is the course table which is having student as well as class. All the student names are given and all the classes given. Now we have to find the class which is having more than 5 students. So take a 2-minute pause. Think that how we can approach this question, and then we will go ahead and discuss the solution. So this is kind of a same question which we solved in the duplicate email. So what we have to do is, first we have got the classes as well as students. So what we will do is we will form the group of all the class. So we'll group the class, and after we have grouped the class, we will count the number of students. So once we have grouped the class, we'll count the number of students, and whenever the count is greater than or equal to 5, we'll print it in the final result. So it was very easy. What we have to do is, first we'll group the class. So we'll group the class according to the value. So there will be a class maths, there will be a group of class English, biology. In this way, there will be multiple groups. Now in all those groups, there would be a students who are enrolled in these particular classes, and then we can count the number of students in this particular groups, and we can see that wherever the count is greater than or equal to 5, we have to return it in final result. So let's see how we can form the query. So first what we would be doing is we will be selecting class, and then we'll give from, and then the table name is courses, and then we will be grouping group by class. So we have formed the group of the class. Then we have to give a condition having count of student count greater than or equal to 5. So this is how we can write the query for the same. First we will be selecting class, then we would be grouping these class, and then we would be counting the number of students which is present in this class. So if the count of student is greater than or equal to 5, we will be returning those classes in the final result. So let's see from lead code how we can solve this. So first what we would be doing is we will be selecting class, and then the table name is from courses. So let me just copy it from here, from courses, and then we will be giving the group by, and then we'll give the column name, that is class. So then we'll give the condition having, then we will give count, and then we'll provide the column name, that is student, greater than or equal to 5. So this is how we can form the query for the same. Select the class from the courses table, group the classes, and then count the number of students in those groups, and if it's greater than or equal to 5, return it in the final result. So let's just run this query. So here you can see that it has accepted and run for the test cases. So let me just submit this. This is how we can approach a SQL question. Now the word transaction may be familiar to many of you. Consider that I want to transfer some money to my friend, and once the payment is successful, I often get the message as transaction is successful. Consider that I am ordering something online, and once the payment is successful here, again I get the message as transaction is successful. So you can understand it in this way, that transaction is basically a collection or combination of some database operations like read, write, commit, rollback, which is used to perform a specific task. So transaction is a logical unit of work that comprises of one or more database operations like read, write, commit, rollback to perform that particular unit of work. So consider there is a person A who wants to transfer 50 rupees to person B. So this is a transaction which is happening here. Now transaction have read as well as write operations, and then there are commit and rollback. So we would be learning about commit and rollback in next set of slides, but let's learn about read and write operation. So a read operation involves retrieving or fetching the data from the database. So whenever we are retrieving or fetching some values from the database, we call it as read operation. It is often denoted by R. Now coming to write operation. So a write operation in transaction involves modifying the data in the database. So whenever we need to modify or update the data in the database, we use this write operation. So it is denoted by W. So let's come back to this example again. Now A wants to transfer 50 rupees to B. So what are the things we need? So first we need what is the current bank balance of A. Consider that if A is having only 20 rupees, would he be able to transfer 50 rupees to B? No. So we need to fetch the current bank balance of A. So first we will do a read operation on A, which is fetching the current bank balance of A from the database. So consider that right now A is having 100 rupees. So we have fetched the current bank balance of A from the database. Now we have to perform this arithmetic operation where we will be deducting 50 rupees from A's current balance. So that would be 100 minus 50. That is 50 rupees. Now A's current balance is 50 rupees. So we have to update this value in our database. But before updating, we need to know that if this particular amount has been transferred to B or not. Consider that we have updated the value of A, but at some point B does not receive 50 rupees. So there will be data inconsistency. So what happens is we do a write operation, we do a modify operation, but this particular write operation goes ahead and update the value 50 in the transaction logs, or you can say a shared memory. So before commit, if there is any operation which happens in a transaction, always go to the transaction log or log records. So this value would be updated in the log records. Now coming to B, again we need to know that what is the current value or current bank balance of B. So we'll do a read operation on B. So it will give me the current bank balance of B, consider 50 rupees. So we have got the current bank balance of B. Now we need to add 50 rupees to B's balance. So we'll do an arithmetic operation. So it will add 50 rupees to current B balance, that is 100 rupees. Now we need to update this value as well in the database. So we will do W of B. This will be W of A. So it will update the value to 100 rupees. Again, this will go ahead and get saved in the transaction logs. We are not saving or updating the value in the database yet. Now we know that all the operations have been successful. The arithmetic operations and everything have been successful. Then we will perform a commit operation. Commit says that if all the operations have been successfully done, then go ahead and update the value in the database. So commit will read everything from the log records, and once log records see the commit, it will go ahead and delete all all the log records and it will get updated in the database. So this is how the transaction happens. So here also there is an example. Consider we are using the Swiggy app, we are ordering something, we go to the payment page, we enter the bank details and we get the OTP. There could be two scenarios. One, there is some network issues or failure. Second, there is no network failure. So when there is no network failure, the order is done, the payment is successful and the transaction is complete. But once there is a network failure which is encountered, there could be two cases. One, the amount is deducted from your bank account. Second, the amount is not deducted from your bank account. So there is a rollback which comes into picture, which says that if at any point there is any failure which is encountered in the transaction before commit, what we do is we roll back it to its original state, so that if there is any amount which is deducted, you will get a message that you will be getting credited this particular amount in your bank balance within 7 days or within 24 hours, because that is a rollback step which is applied. So if you are entering your OTP and some amount is deducted from your account, but still the order is not completed or the order is not done, you will get that particular amount back in your bank balance, or you will get that particular amount refunded. So consider an example of a banking application where a customer Ram wants to transfer 100 rupees to Shyam. So let's see all the steps which we discussed here only, but let's see how these steps execute. So the step 1 is we have to begin the transaction. The step 2 is the application will fetch or read the current balance of Ram, since Ram wants to transfer 100 rupees to Shyam. So we'll fetch the current bank balance of Ram. So that would be read of Ram. Now the step 3 is the application will calculate the new balance after the transfer. So that would be current balance of Ram minus 100 rupees. So consider right now Ram is having 200 rupees. So we have to deduct 100 rupees from current bank balance of Ram. That would be 100 rupees. So we have performed the arithmetic operation. Now the step 4 is we have to update it in the temporary storage or transaction logs. That is W of Ram, that is write of Ram. So why we are updating it in the temporary storage or transaction logs? Because consider that if we are deducting something from Ram balance, this particular amount should be transferred to Shyam. If at any point while transferring there is a failure which has happened, so we need to take care that if the transaction is successful, only then go ahead and update in the database. Before that, update it in the transaction log, so that we have logs of everything, but we are not updating any inconsistent data in the database. Now the step 5 is the application will fetch and read the current bank balance of Shyam. Then step 6 is the application will calculate the new balance of Shyam after the transfer. Consider Shyam is having 100 rupees. So after the transfer, Shyam is having S plus 100, that is 100 plus 100, that is 200 rupees. Now the step 7 is we have to update it in the temporary storage or transaction log, that is W of Shyam, since we are modifying the data. Now step 8 is if all the updates are successful, at all these steps everything is successful and there was no failure and there are no errors, commit the transaction to make the changes permanent. So we have to perform a commit operation at the end of transaction so that all the changes are permanent and it's updated in our DB. So it will go ahead and update in our DB. Logs are maintained till the occurrence of commit. After that, log files are deleted and database is updated. So before the commit, all the log files and everything is maintained, but once it encounters commit, it deletes all the log file and it goes in and update in the database. Now the step 9 is if an error occurs during any step, roll back the transaction to revert the changes made within the transaction, that is rollback. So consider at any step from step 1 to step 7, there is any issues which we have encountered or the transaction has failed because of network failures, data failures or things like that. So what we have to do is we have to perform a rollback so that everything is reverted back to its original state and there is no data inconsistency which is present in our database. So rollback is often introduced whenever we encounter error or any issues at any point of the transaction. So this is all about the steps involved in the transaction. So considering the last example, let's learn about transaction state. So this was the transaction log for the last example. First we begin the transaction, then we read the value from Ram, then we do the arithmetic operation, then we write in Ram, then we read the value of Shyam, we do the arithmetic operation, we update the value of Shyam, then we do commit so that all the data is pushed into the database if everything is successful, and we perform rollback if we encounter any issues still here. So the case 1 is where all the operations are successful and we are updating updating the data into the database. So the very first step is the active state. So the active state occurs that whenever the transaction is begin and we start performing the database operations, at that particular moment the active state occurs. So here you can see that before commit, whatever is the operation which is being performed, we say it as a partially committed state, because if at this point there is any failure encountered, we roll back the entire transaction, or if at this point there is a success occurred, so we commit the transaction. So we call it as partially committed state. Now coming to commit, so this is a successful state. We can say now we have come to a successful state and now we can update the data into our database. And then after rollback there is a completed state. The transaction is completed. Now coming to case 2, where we encountered some failures during the transaction. So again, when we are reading the value, it's the active state. After the begin statement, whatever operation we are performing is the active state. If before the commit operation, whatever operation is getting performed, if it fails somehow, then we call it as a failed state. And then commit state is called as cancelled or rollback state, because we don't commit, we rather roll back. So if there is any issue which is encountered at this stage, we come to rollback. If not, then we come to commit. So we will cancel or roll back, and then the transaction is completed, even though it's failure, but the transaction has been completed. Now we again need to do the transaction. So these are all the states which are involved in a transaction. Let's learn about concurrency control. So concurrency control ensures that multiple transactions can run concurrently without compromising the data consistency. So if there are two transactions, T1 and T2, it ensures that T1 and T2 can run concurrently or parallelly without compromising the data consistency. That is, data should be similar for both the transaction. There shouldn't be any data inconsistency. So consider an example where there is a banking system where two transactions are happening concurrently or parallelly. So Ram is giving 100 rupees to Shyam and Shyam is giving 50 rupees to Ram. So the data should be consistent for both the transaction, because if Ram is giving 100 rupees to Shyam, we have to deduct 100 rupees from Ram's current balance. And if Shyam is giving 50 rupees to Ram, we have to deduct 50 rupees from Shyam's bank balance. So these two are happening concurrently and as part of the same values. So we can say that the data should be consistent as part of this concurrency control. So if there are two transactions, T1 and T2, and if as part of T1 also we are updating some value, and if part of T2 also we are updating some value, the data should be consistent. It shouldn't be a case that if we are updating some value here, then we are going here and reading the same value and then updating the new value. It shouldn't be the case. The transaction should be isolated of each other. So if there are any concurrent or parallel transaction, that should happen without any hindrance to the data consistency. So there are some techniques which are often used to manage the concurrency control. First is locking, second is two-phase locking, and third is timestamp ordering. So we can use these techniques to manage the concurrency control in our database. Now what are these ACID properties? So ACID properties are the properties which ensures that the transactions are processed reliably and accurately even in complex situations like system failures or network issues. So if we encounter any complex situations like system failures, network issues while having a transaction, it makes sure that the transaction is accurate and reliable. So ACID properties are the properties which make sure that our transaction is processed reliably and accurately. Now coming to the acronym ACID. So A stands for atomicity, which means that either execute all the operations or none of the operations should be executed. Coming to C, that is consistency, which says that read should fetch up-to-date data and write shouldn't violate any integrity constraints. Now coming to I, that is isolation. So one transaction should be independent of other transaction, that is they should be isolated. Now coming to D, that is durability. So the committed transaction should remain even after a failure or crash. So if we update the value in the database, that should remain even after we fail any failure or crash. So let's learn about each and every in depth. Now coming to A, that is atomicity. So it ensures that a transaction is treated as a single unit of work. Either all operations are completed successfully, that is commit, or none of them are applied, that is rollback. So as I told in the earlier videos as well, that if at any point there is any failure which is encountered in the transaction before the commit, we often perform the rollback, that is we revert back it to its original state. So it says that either all operations should be completed or none of them should be applied. So if there is a transaction, consider there is a transaction begin, we read a value from A, we update the value of A, and then we perform the commit. If at any point here, if the transaction fails because of some network failures or other issues, we have to perform a rollback. So we will perform a rollback and it will go back to its original state. And if at any point there is no failures, then we perform the commit and the data is updated into our DB. So this guarantees that the database remains in a consistent state despite any failures or interruptions during the transaction. It ensures that our database remains in a consistent state because consider that if I have updated any value into our database and if there are some more operations which are being performed on the same data, then there should be inconsistency which will be present. Now consider an example. So consider Ram is transferring money to Shyam. The transaction must deduct the amount from Ram's account and then add it to Shyam account as a single operation. If at any moment or at any part this transaction fails while transferring amount from Ram to Shyam, example due to insufficient funds, system error, network error, the entire transaction is rolled back, ensuring that none of the account is affected partially. So if there are transaction which is happening between two accounts, Ram and Shyam, and if we are transferring any amount of money from Ram to Shyam, if at any point there is any failure which is encountered, because consider maybe we are transferring 100 rupees to Shyam and Ram's current balance is only 50 rupees. So we are encountering an issue because Ram is having insufficient balance. So we should roll back this transaction and it should come to its original state. So let's learn about consistency. So consistency ensures that first, read operations retrieve consistent and up-to-date data from the database, and second, write operation ensures that the data modification maintain database constraint such as foreign key relationship, unique constraints, so that the data remains accurate. So consistency says that the data should be consistent. Now whenever we are performing any read operation of any of the data, consider we are reading the value of A, so it should show me the up-to-date data, like the last updated value of A should be shown while doing the read operation. And coming to the write operation, so if I'm doing any write operation on the A, so it should ensure that the data modification maintain database constraint. So if there is any constraint which is applied, consider that it is a primary key, so I can't update any duplicate value in it, right? So these constraints should be maintained and these constraints should be taken care while updating any value in the database. So it guarantees that the database remains in a consistent state before and after the execution of each transaction. So it ensures that our database should be in a consistent state before and after execution of any of the transaction. So consider A is transferring 10 rupees to B. So what we need to do, first we'll fetch the current value of A. So the current value of A is consider 50 rupees. Now we need to perform the arithmetic operation where we need to deduct 10 rupees from A. So that would be 50 minus 10, that is 40 rupees. So we will write the value of 40 in A. Now we need to fetch the current value of B. So we'll fetch the current value of B, consider 20 rupees. Now we need to update the value of B. So B will be having 10 rupees extra. So that would be 20 plus 10, that is 30 rupees. Now we have to write this particular value in B, that is 30 rupees. So before the transaction, if you see, A was having 50 rupees and B was having 20 rupees. So 50 plus 20 gives us 70. Now after the transaction, if you see, A is having 40 rupees and B is having 30 rupees. If we again do the addition, it is 70. So you can see that data is consistent before as well as after the transaction. So consistency basically ensures that the data should be consistent. If we are reading any value from the database, it should give me an up-to-date value. If I'm writing any value or updating any value in the database, I should follow the integrity constraints so that the value which is being updated is not a wrong value or doesn't violate any of the integrity constraint. Now consider an example. Consider you had 100 rupees in your account, but you want 50 rupees cash. So you transferred 50 rupees to a person X and he gave you 50 rupees cash. Now before the transaction, you are having 100 rupees in your account. Now after the transaction, again you are having 100 rupees, 50 rupees you have in your account and 50 rupees is the cash which you got from the person X. So you can see that the data is consistent before as well as after the transaction. Now coming to I, that is isolation. So it ensures that if there are two transactions, 1 and 2, then the changes made by transaction 1 are not visible to transaction 2 until transaction 1 commits. So if there are two transactions which is happening, consider on the data A only there are two set of transactions happening. So as part of first transaction, we are increasing the value of A by 10, and as part of second transaction, we are decreasing the value of A by 10. So while the transaction is reading the data, the DBMS ensures that the data is consistent and isolated from other transactions. So these two transactions should be isolated from each other. This means that the other transaction cannot modify the data being read by the current transaction. So consider if T1 is the current transaction, T2 can't be performed until or unless T1 is committed or all the operations are done successfully. Only then T2 can go ahead and read the updated value which is being updated here. So until it's committed or rolled back. So if this transaction is committed or if there is any rollback which is performed, we have to wait for this transaction to complete. Only then T2 can go ahead and read the value of A and perform its operation. So here is an example. Consider A is having 40 rupees in the DB. So transaction 1 is updating the value of A to 50 rupees. Transaction 2 is reading, getting or fetching the value of A. So if transaction 1 is committed, according to transaction 2, the value of A would be 50 rupees. As in transaction 1, we are updating the value of A to 50 rupees. So now 40 would be updated to 50. And since this transaction is committed, now T2 can fetch from the current value, that is 50 rupees. Now if transaction 1 is in pending or running state, according to transaction 2, the value of A would be 40 rupees because still the transaction 1 is not completed. So if we read the value of A, it would be 40 rupees only because the write operation has not been completed. It's in pending or running state. So the value of A would be 40 rupees. So you can see that there is data inconsistency. That is why it said that if there are two transactions which is happening, we have to wait for one transaction to be completed or committed before starting the second operation, which involves the modifying the same data which transaction 1 is also modifying. So two transactions should be isolated of each other. So let's learn about D, that is durability. So it ensures that once you save your data, that is commit a transaction, it stays saved even if the system crashes or there is a power failure. So consider you saved your data into the database and immediately after that there is a system failure or there is a system crash. That particular data would be saved in your database. That particular data won't be lost. So your data is always safe and won't disappear after you save, as committed transactions are not lost. So if you commit a transaction, that could never be lost even if there is any system failure or any network issue. If your transaction is committed, the data is saved, it's not lost. So most DBMS use a technique called as write ahead logging, that is WAL, to ensure durability. Before modifying the data in the database, the DBMS writes the changes into a transaction log which is often stored on a disk and in a sequential manner. This ensures that if there is any failure event, the database can recover to a consistent state. So how a transaction takes place? So consider that if there is a transaction where A is transferring some amount to B. So what A will do, A will fetch the current value, then A will do some arithmetic operation, and then after doing the arithmetic operation, A will update its value. So once A updates its value, this particular log is saved in the transaction log. So when we do write of A, it is not saved into the database, it is rather saved into the transaction log. And transaction log is deleted once we encounter the commit. So using this transaction log, we can recover our DBMS to a consistent state. So consider an example, if you are transferring 100 rupees to your friend and there is a sudden power outage or system crashes right after the transaction is committed. The changes, the transfer of 100 rupees will still be saved in the database. When the system is back up, both your account and your friend account will reflect the updated balance. So once the system is back up, it will show the updated amount to him as well as his friend. So this makes sure that even if there is any failure, everything is getting saved into our database and we have transaction logs to monitor each and everything at each and every point of transaction. So let's re-revise about ACID properties. So A stands for atomicity, which tells that either all operations should be executed or none of them should be executed. C stands for consistency, which says that if we are performing any read operation, the data should be up to date. If we are performing any write operation or update operation, we should be following the integrity constraints to update the value. Now third is isolation, which says that if there are two transactions, they should be isolated of each other. That is, first transaction should commit before the second transaction start. Now coming to durability, it says that if there are any committed changes in our database, that should be reflecting, that should be saved even if there is any system crash or network failure which has happened. Now before starting with isolation level, let's just understand about isolation. So isolation says that if there are two transactions T1 and T2 which is running parallelly or concurrently, you can say, then these transactions should be isolated of each other. That is, if there are any operations which is happening in T1 should be isolated of operations which is happening in T2. Now this is what isolation is. Now what is this isolation level? So isolation level is the extent to which these operations are isolated of each other. Now whenever there is a read or write operation happening in T1, how much it is isolated with read and write operation happening in T2. So that is what isolation level is. It is the extent to which the isolation in the operations happens. Now why do we need to learn about isolation level? So in systems where multiple transactions are executed concurrently you can say parallelly, like there are threads on which the transactions are getting executed. So isolation levels manage the extent to which the operation of one transaction are isolated from those of other transaction. So the extent to which operation of one transaction are isolated to those of other transaction, that is isolation level. And we need isolation level because in systems there are sometimes multiple transaction which happens. So we need to know the extent to which, if there are multiple transaction happening, what is the extent to which their operations are isolated of each other. Now isolation level help us to prevent common transactional anomalies. So there are some anomalies which happens while transaction, and isolation level help us to prevent them. Now what are these anomalies? So the first anomaly is dirty read. Now dirty read happens whenever we are reading uncommitted data from another transaction. So consider that there are two transactions T1 and T2, and as part of T1 I am writing some data in A, but as part of T2 I am reading some data of A. So as I have written some data into A, this particular data is updated in my internal memory. So if the value of A was 10, I have updated the A value to A plus 10. So now A value would be 20. And if I am reading A, then I'll be reading 20, not 10, because it is updated in the internal memory. It's not updated in the database yet because we haven't committed this transaction, but it's updated in the transaction logs, or you can say internal memory. And what if this transaction fails at some point? So if the transaction fails, we do a rollback and then A value would be updated back to 10. But here I have read the value of A to 20, so this becomes irrelevant. So that is why dirty read happens whenever we are reading any uncommitted data from another transaction. Now what is this non-repeatable read? So non-repeatable read happens whenever data changes after it has been read within the same transaction. So consider that as part of T1 I am reading some data. As part of T2 I am updating that particular data, and as part of T1 again I am reading the same data. So here if the value of A was 10, if I updated the value of A to 20, here if I again read the value of A, it will come as 20. So during the read operation I can see that first read operation gave me 10, but second read operation gave me 20. So the data changes happened, and after it has been read within the same transaction. So within the same transaction, if there are two read operations which are happening, and if in the next transaction there is any write operation which has happened, the values would be changed. Now coming to phantom read. So phantom read says that new rows are added or removed by another transaction after a query has been executed. Now consider that there is an employee table. In that particular employee table right now there are two records of employee E1 and E2. Now consider if I am doing a get query here. Right now I am getting two records, but consider if a new employee enters this particular organization. So I'll add that particular employee details as well in my table. Now again if I do a get on this particular table, it will give me 3 records. So you can see that the records has been changed. Again consider that if E2 decides to leave the organization, so we'll delete E2's entry from our DB or from our table. Then again if we do a get, then we'll again get 2 records. So you can see that whenever there is some insertion or deletion happens, the get or the fetching of values or finding of values gives us different set of records. So new rows are added or removed by another transaction after a query is executed. It causes the phantom read. Whenever we are reading any uncommitted data, another transaction, dirty read happens, and whenever there is some data changes which happened in the same transaction, that is called as non-repeatable read. So these are some of the anomalies which are taken care as part of isolation levels. Now consider that if there are two transactions which is happening read as well as write operation, so there could be 4 possible combinations where if transaction 1 is executed and transaction 2 is executing, what are the operations they would be persisting. So the first one is transaction 1 can read value value, transaction 2 at the same time can read value. Now coming to the next possible combination, transaction 1 can read value, transaction 2 can write the value as well. Now coming to the third combination where transaction 1 can write the value and transaction 1 would be reading the value. Coming to the fourth one where transaction 1 is also writing the value and transaction 2 is also writing the value. Since transaction 1 has read and write operations and transaction 2 also had read and write operations, we kept 1 as constant and then we switched between the different operations which were present here. Again we kept write as constant and then we switched between the different operations which is present here. So these set of operations can happen while two transaction is happening. So what is isolation level? It determines the degree to which the operations in one transaction are isolated from other transaction. So if there are two transactions T1 and T2 and if there are some set of operations which is happening between these two transactions, what is the extent to which these operations are isolated of each other? Now here we can see that there is a diagram on how a transaction happens. So consider that if there is an application, as part of application there could be multiple transactions. So there is two transactions T1 and T2. Now T1 can also have some operations and T2 can also have some operations. So what we do whenever we perform any operation in any of the transaction, we go ahead and save it in our transaction logs. We don't go ahead and save it in the database directly, because if there are multiple transactions happening, there could be a possibility that there is some failure which is encountered and some of the transaction fails. Because of that, we don't go ahead and directly update in the DB. We go ahead and save it in the transaction logs, or you can say in the internal memory. And once the transaction is committed, we can say now it is ready to get saved in the database. We delete the transaction logs and we go ahead and save that particular into our DB. So this is how a transaction takes place. Now let's learn about anomalies in more depth. So the first anomaly is dirty read. So reading the data returned by a transaction that has not yet been committed. So let's understand from an example. Consider we are doing some changes into this A, and right now the value of A is 10. As transaction T1 we are updating the value of A to 20. Updating A to 20, and as part of T2 we are just reading the current value of A. So right now the value of A is 10. We updated the value of A to 20 as part of T1 as there is a write operation, and as part of T2 we are reading the value of A. Right now the A value from 10 it is updated to 20, so we will be reading 20. But consider that at some point this transaction fails. T1 fails. So whenever a transaction fails, there is a rollback which says that revert it back to its original state. So we have to revert back all the operation and we have to again go ahead and revert the value of A which we updated to 20 to 10. Now the value of A is updated to 10, but as part of T2 we have read the value of A, and right now we know that the value of A is 20, but here the value of A is 10 as this particular transaction at some point failed. So you can see that this particular data or this particular read operation which we have performed is irrelevant, because now this particular data is irrelevant because in our database the value of A is 10. So whenever there is a transaction T2 which reads the data which is written by transaction T1, and if T1 fails, it becomes irrelevant, because right now when we are doing a read operation from T2, it is reading the incorrect or data which is not present. So you can say a stale data. So it's reading a stale data and it is performing all its operation on the stale data. So whenever there is a write read happening, we call it as dirty read. Now let's learn about the next anomaly, that is non-repeatable read. So it says that reading the same row twice within the transaction and getting different values because another transaction modified the row and committed. Consider again we are doing some read-write operations on A. So as part of T2, what we are doing is we are updating the value of A again to 20. And as part of T1, we are reading the value of A and doing some operations. You can say reading the value plus doing some external operations that we are not sure right now. Doing operations. So what happened? As part of T1, we read the value of A, so that is 10. As part of T2, we read the value of A, again it is 10. We write the value of A, so now A is updated to 20, so it will be 20. And then we commit the changes, that is this 20 is now saved into our database. Until this point, it was saved into our transaction logs, or you can say internal memory. But whenever we encounter this commit, it is saved into our database. So right now the value of A is 20. So consider that because of some issue the T1 transaction stopped and it again began, and now again it is starting reading the value of A. Now here if it do a read of A, it will give me 20 as the 20 is updated in our database. But here if we read the value of A, it was 10, and on this 10 we were about to perform some operations, but right now we need to perform the operations on 20. So you can see that if there are multiple read which is happening in same transaction, and if another transaction commits some value or writes some value, then there is a non-repeatable read which happens. So consider if T2 modifies the data which T1 is already reading, and if T1 continues the transaction, the data will be changed. So here the data was 10 and here the data was 20. T1 stopped in between for some unknown reasons, and if T1 again started, it will read some changed data. So here the value was 10, but here the value has been updated to 20 because another transaction read the same data and committed on the same data. So whenever we are having some multiple reads in one transaction, and because of another transaction the multiple reads are giving different values, that is called as non-repeatable read. Now coming to the third anomaly, that is phantom read. So getting different set of rows in subsequent queries within the same transaction because another transaction inserted deleted rows and committed the data. So the same example, consider that there is an employee table. Right now we have 2 employees present in our table. First what I am doing, I am fetching the name of the employees. So right now I'll get only 2 values for the name of employees. Now consider that there is another transaction T2 as part of which we are inserting some data into our DB, or we are inserting new employee details E3 who has recently joined the company. So we have inserted the value of E3. Now names will be giving me 3 values. So again if I fetch the name, it will give me 3 records, and here it was giving me 2 records. So you can see that here I was getting 2 records, but here I was getting 3 records because another transaction came and inserted a new set of data here. Again there could be a deletion as well. Consider that if E2 left the organization. So as part of T2 I can go ahead and delete the entry of employee 2 as well, and again if I fetch the names, I'll get the only 2 values. So you can see that there is some discrepancies in the records which we are getting while fetching because some other transaction came and inserted or deleted some of the records from our table. So this is the phantom read. Now we learnt about isolation level, we learnt about anomalies, but let's learn about types of isolation level. So there are 4 types of isolation level which help us with these anomalies. So the first one is read uncommitted, the second is read committed, the third is repeatable read, and the 4th is serializable. So let's learn about each and every one of them. So let's learn about the first isolation level, that is read uncommitted. So it is the lowest isolation level where transaction can see uncommitted changes made by another transactions. So if a transaction can see uncommitted changes made by another transaction, that is read uncommitted isolation level. So as you can see from the word also, it says that read uncommitted. So one transaction can read uncommitted changes. If a transaction T1 is writing a value to a table, T2 can go ahead and read that particular value before T1 commits. So if there are 2 transactions T1 and T2, if T1 is writing some value to a particular table, T2 can go ahead and read that particular value even if T1 is not committed. That is why it is called as lowest isolation level. So here you can see that there is a write read problem which is happening, because of which it doesn't takes care of dirty reads. The dirty reads is still there in this particular isolation level. Non-repeatable reads is also present here because again I can go ahead and read that particular value after some point in T2 and it will give me another data. Phantom read is also here because as part of this transaction we are not waiting for this transaction to commit, so we can go ahead and as part of T2 we can insert some data or delete some data from a particular table. Now coming to the next level, that is read committed. So it says read the value only when it is committed. So it ensures that any data is read during the transaction is committed at the moment it's read. So if there are 2 transactions T1 and T2, and if as part of T1 I am writing some value to A and as part of T2 I am reading some value of A, I can only perform this read operation whenever this particular transaction is committed and the data is saved into our database. So if T1 has done some write operation, T2 can only read the data when T1 has committed. So here you can see that after the commit I am reading the data, so there is no chances of T1 getting failed. So this read write problem is taken care here. So there is no dirty read which happens here. Now coming to non-repeatable reads. Non-repeatable reads can happen because consider here I am reading a data and again in this transaction T1 I am writing something and again I am reading the data. So here and here the data would be different. So non-repeatable reads can happen. Now coming to phantom reads. Phantom reads can also happen because what if transaction T2 comes and inserts some new record into the table. So that is why phantom read will always happen and non-repeatable read can also happen. Now coming to the third, that is repeatable read. So it ensures that if one transaction reads a row, it will see the same values for that particular row during the entire transaction. Even if other transaction modifies the data and commit, if transaction T1 reads the value, transaction T2 cannot go ahead and modify the value until T1 completes. So how this read read and read problem was happening. Consider as part of T1 and T2. T1 I was reading some value, as part of T2 I was writing some value, but because of some issues T1 stopped, and after some time again it started. So if I read the value here and if I read the value here, they were different. But according to repeatable read, if a transaction reads a row, it will see the same value of row during the entire transaction, even if other transaction modifies the data and commits. So even if T2 commits the data or modifies the data, T1 will always read the same data which it read during the start of the transaction. So because of this, dirty read is stopped. Non-repeatable read will also not happen, because it says that if there is any modification done as part of other transaction, that should wait until transaction T1 is complete. But it says that T2 can go ahead and insert some new rows. So because of this, phantom read is still existing here, but dirty reads and non-repeatable read is taken care. Now coming to the next transaction level, that is serializable. So it ensures that there is a serial transaction execution so that there is a complete isolation. So whenever there is a serial transaction execution, that is if there are two transactions T1 and T2, T2 should wait for T1 to complete. So if transaction T1 is executing, T2 must wait until T1 is complete. So if transaction T2 is waiting for T1 to get completed, it can't go ahead and insert any new row because T1 is still in progress. It can't go ahead and read some particular value or make modification to that particular value because again T1 is in progress. And it can't go ahead and read some particular value because again T1 is in progress. So there won't be any dirty reads because there is no read-write anomalies or write-read anomalies because T1 needs to be completed before T2 gets started. There is no non-repeatable read because again T2 has to wait for T1 to complete, and then only it can perform any read operation. Now coming to phantom read, that will also not happen because T2 can't go ahead and insert any new row until T1 is completed. So T1 should be completed for T2 to start. So there should be completion of T1 before T2. So that is why serializable has the most extent of isolation. Now what is a schedule? So schedule refers to the sequence in which a set of concurrent, or you can say multiple transactions are executed. You can also say it as a sequence in which the operations such as read, write, commit and abort of multiple transactions are getting executed. So consider if there are two transactions T1 and T2. As part of D1 we are doing some read operation, as part of T2 we are doing some write operation. So the time order sequence in which these operations of multiple transactions are getting executed, that is what a schedule is. Now it is really helpful to ensure data consistency and integrity. Since it tells us that what is the sequence in which the operations are getting executed, it is very helpful in maintaining the data consistency and integrity of database. Consider if there are some transaction T1, T2 till Tn, then the possible number of schedule is n factorial. So if there are two transactions, the possible number of schedule is 2 factorial. Now here if you can see, there is a schedule SC1 where we have two transactions T1 and T2. We have mentioned all the operations which are happening in these two transactions, including the read as well as write operation. Now here you can see that we are getting a time order sequence, like first T1 started its read operation, then there was a context switch, then T2 started its execution, then again there was a context switch, then T1 committed the data, then again there was a context switch and T2 committed the data. So we can know the time order sequence or the sequence in which the multiple operations of different transactions are getting executed. Now here you can see that in the schedule we can see the commits. So if commits are present in the schedule, we call it as a complete schedule. If commit statement is not present in the schedule, that is changes are not saved into the database, we call it as incomplete schedule. So let's see in more depth. So incomplete schedule is a schedule where not all transactions have reached their final state of either commit or abort. So final state in any transaction is either commit or you can say rollback. So if the transactions succeed, we commit all the changes into the database. If transaction does not succeed or face any network failure or system failure, we roll back all the changes. So whenever some of the transaction in a schedule does not reach its final state, we'll call it as incomplete schedule, and when they reach, we call it as complete schedule. So here you can see that there are two transactions T1 and T2. T1 performed some read as well as write operation, then there was a context switch, then T2 performed some read as well as write operation, then there was a commit which was done for T2, but there was no commit which was performed for T1. So we can say that this is an incomplete schedule because T1 hasn't reached to its final state and is still in progress. So whenever any part of transaction which is a part of schedule which hasn't reached to its final state, we call it as incomplete schedule. Now coming to complete schedule, so a complete schedule is one where all transactions in the schedule have either committed or aborted, basically have reached their final state. So here if you see, there are two transactions T1 and T2. T1 started its execution and reached its final state, so T1 is already in its final state. Coming to T2, T2 started its execution and reached its final state. So here both of the transaction T1 and T2 are in final state, so we can call it as a complete schedule. So basically if the transaction in a schedule has reached its final state, we call it as complete schedule. If they haven't reached its final state, we call it as incomplete schedule. Now coming to the types of schedule. So the first one is serial schedule, the second one is concurrent or non-serial schedule, third is conflict serializable, fourth is view serializable, fifth is recoverable, sixth is irrecoverable, seventh is cascadeless, eighth is cascading, and ninth is strict schedule. So let's learn about each and every schedule in depth. So coming to the serial schedule. So a serial schedule is one where transactions are executed one after another. We can say it like if there are two transactions T1 and T2, then T1 should commit to completion before T2 starts. So according to serial schedule, if there are two transactions T1 and T2, so T2 should only start when all the operations of T1 are committed or either saved in database, or we can also say have reached their final state. So once they have reached their final state, only then T2 can start, else T2 can't start. So if you see the schedule here, there are two transactions T1 and T2. T1 started its execution, read A, write A, and then there is a commit. So T1 has reached to its final state. Now only T2 can start, before this T2 can't start. So there is a serial execution. First T1 will complete all its operation, then T2 will start its operation and complete it. Then T2 started and here T2 also completed. So you can say that T2 starts only after T1 is completed, committed, or reached its final state. Now here you can see that there is a serial execution which happens, like first transaction T1 will be completing, then only T2 will be starting. That is why it is known as serial schedule, because it has serial execution of transactions. So let's see the advantages and challenges which is faced in the serial schedule. So coming to the first advantages, it follows the ACID properties, that is transactions are isolated from each other. So in the serial schedule, what happens is, if there are two transactions T1 and T2, T1 needs to perform all its execution, only then T2 can start. So we can say that these particular transactions are isolated of each other. Any operation of T2 can't go ahead and hamper any operation which is getting performed in T1. So there is a level of isolation which is maintained between T1 and T2, because T1's all execution are done, only then T2 starts. Now the second point is it maintains consistency. So consistency is obviously maintained here because T1 is committing all the changes into the database once it's succeeding. So even if we start T2 and even if we perform some operation on the same data item, all the data has been updated into the database. So there is no data inconsistency which would happen, because there won't be any read, write, read conflicts which would be occurring. So we won't be going ahead and updating any invalid data in our database. T1 has committed all the changes, T1 has successfully updated it in the database, and then only we are performing operations of T2. So let's see the challenges. First challenge is, since there is a poor throughput, that is number of transactions completed per unit time, and the memory utilization is also poor, that is why it is not suggested, as it can be inefficient. So consider in the serial schedule, if there are two transactions T1 and T2, T2 needs to wait for T1 to get completed, but consider T1 take 5 minutes to get completed. So T2 can only start after 5 minutes. So if you see the throughput, that is number of transactions completed per unit time, is very less. That is why there is a poor throughput. And memory utilization is also poor, because if T1 is executing all its operation, T2 is sitting idle, and CPU core is only able to succeed all the T1 operations, not the T2 one. So T2 is sitting idle and CPU cores are also not getting utilized to its max. So we can say the memory utilization is also poor. The second is, since wait time is high, less number of transactions are completed. Now T2 needs to wait for T1 to complete, and T1 is taking 5 minutes. So the wait time is very high. In 5 minutes, in a real life scenario, there should be 1,000 or more than 1,000 transactions which should be done. But here, in that particular time, only one transaction is getting completed. Because of all these reasons, it is suggested not to use the serial schedule, even if it has a higher consistency, but the throughput is very low, the number of transactions getting completed per unit time is low, memory utilization is low, or you can also say the wait time is very high. So because of all those things, serial schedule is not suggested. Now coming to the second schedule, that is a non-serial, or you can say concurrent schedule. Now from the name it's clear, non-serial, so there is no serial execution. So a non-serial schedule is one where multiple transactions can execute simultaneously. Operations of multiple transactions are alternate or interleaved. So what is this alternate or interleaved? So here if you can see, there are three transactions, T1, T2 and T3. Here T1 started its execution, then there was a context switch. T2 started its execution, then again there was a context switch, and then T3 started its execution. So all these transactions are starting their execution simultaneously. So these are interleaved, or you can say alternate execution. We can say it like if there are two transactions T1 and T2, T2 doesn't need to wait for T1 to commit, it can start at any point. So if you see from example, T2 or either T3 can start their execution, they don't need to wait for T1 to get completed. That is what a concurrent schedule is. So here T2 didn't waited for T1 to commit. Now here you can see that at later point T1 is committing its changes, but T2 and T3 have started their execution. So the wait time is very low. Now coming to the advantages and challenges, first is better resource utilization, because at the same CPU core T1 is also starting their execution, T2 is also starting, T3 is also starting. So resource is getting utilized at its max. Second is wait time is not involved, because T2 doesn't need to wait for T1 to get completed. One transaction doesn't need to wait for running one to finish. So the next is throughput is very high, that is the number of transactions getting completed per unit time, because T1, T2, T3 all are starting at some instant of time and they are not waiting for other one to complete. So it is starting at this particular point, it is starting at this time, it is starting at this time. So at some time T double dash, we will be able to get all these transactions getting completed. So the number of transactions getting completed per unit time would be more. Now coming to the challenges. So first is consistency issue may arise because of non-serial execution. It requires robust concurrency control mechanism to ensure data consistency and integrity. Now in non-serial execution, what happens if there are three transactions T1, T2 and T3? As part of T1 we are reading some data item, as part of T2 we are writing some data item, as part of T3 we are reading some data item. So we have read the data item A, then we have written or updated some value of data item A, then again we have read the value of A. But consider at some point this T2 fails. So this particular transaction T3 has read the value which was there in T2 or which was updated from T2, right? But this particular transaction failed, so there won't be any update happen. But as of now the T3 has read the value which was updated here. So this particular value becomes invalid and there is data inconsistency which happens. So that is why there are some concurrency control mechanism which make sure that these particular things doesn't happen, and serializability concept is also there for this. So we can use serializability and concurrency control mechanism to ensure consistency so that none of the invalid data is updated or there is no inconsistent data which is present in our database. So coming to the third schedule, that is conflict serializable schedule. So a schedule is conflict serializable if it can be transformed into a serial schedule by swapping adjacent non-conflicting operation. Now what are these conflicting and non-conflicting operation? So consider if there are two transactions T1 and T2, we can perform some operations on them. Consider there is a read operation on T1, read operation on T2. Read operation on T1, write operation on T2, write operation on T1, read on T2, and write in T1 and write in T2. So here if you see, if we perform read operation on T1 and T2 both, so they are reading the same data item although, but they are reading the same value, right? They are not updating anything, they are reading the same value, so there is no issues here. But coming to here, if any transaction we are reading some value and at part of next transaction we are updating that particular value, so there will be a read write conflict. Coming to this, so if at part of one transaction we are writing some value or updating some value, and as part of another transaction we are reading that particular value, so there will be a conflict. Coming to the same write, if we are writing some value as part of one transaction and then again writing some value of part of another transaction, so there will be a conflict, because there could be a possibility that we are reading some value and here we are updating some value, but at some particular point this particular transaction fails. So if we are reading the value again, we will be reading inconsistent value. So these all operation can cause inconsistency. You can say that whenever there is a write operation involved, it can cause inconsistency. So we call these pairs as conflicting pairs. Because of these, there could be some conflicts which can arise, or there could be inconsistency in data which can arise. And this pair is non-conflicting because even if we are performing read operations as part of multiple transactions, there is no issues. So here you can see the conflict pair is read write. write read, write when performed on the same data item. But there could be a possibility that as part of T1 I am reading the value of A, but as part of T2 I am writing the value of B. So here the data items are different. So these are also a non-conflicting operation. So if we go to the non-conflicting pair, read when performed on the same data item, read when performed on the different data item, write when performed on the different data item. Since we are performing on different data items, so there would be no consistency issue, because we are not going ahead and updating the value of B, we are going ahead and updating the value of A, and we are reading the value of B, so there won't be any issues. So let's come back to the conflict serializable schedule. So as part of conflict serializable schedule, what we do is we take the concurrent schedule, we change its execution from non-serial to serial, so that the consistency issue which was coming in non-serial execution, or you can say in the concurrent schedule, is encountered or taken care. So what we do here is we find a conflict equivalent. How we can find a conflict equivalent? By swapping the adjacent non-conflict pairs. And in that conflict equivalent, we see that if by swapping we are able to achieve a schedule where there is no conflicts. So coming to this schedule, if we see the non-conflicting adjacent pair, so T1 has read of A, T2 has read of A. So this is a non-conflicting pair because we are performing only read operation on the same data item. Coming to T2 and T1 again, read of A, write of A. This is conflicting. Coming to here, write of A, again conflicting, and then write of B. So here we can see that there is only one non-conflicting pair. So what we have to do is we have to swap these non-conflicting pairs, and then we can get the conflict equivalent, and then we can see that if that conflict equivalent has any conflicts or not. For now, we won't be looking much more depth into this particular schedule because we have a dedicated lecture on conflict serializable schedule. So here you can see that RA of T1 and RA of T2 is non-conflicting, RA of T1 and WA of T2 is conflicting, having read-write conflict, and WA of T1 and WA of T2 is conflicting because they have write-write conflict. So the fourth schedule is view serializable schedule. Now it is also part of serializability. So serializability is a method which is used so that we can encounter the inconsistency issue which was coming in the concurrent schedule. As part of serializability, we do a conflict serializability and a view serializability. So we would be learning about all these in next set of lectures. So view serializability ensures that the database state seen by the transaction in a concurrent schedule can be replicated by some serial execution of those transactions. So in view serializable schedule, or you can say view serializability, we are making sure that if there is a concurrent schedule, they have a serial execution so that the consistency issue is encountered. Now, whenever we find a cycle in our conflict graph, we don't know if our schedule is serializable or not, so we use the view serializability here. So serializability is used to encounter the inconsistency issue which was coming in our concurrent schedule. Now, as part of serializability, there is conflict and view serializability. In conflict serializability, we draw a conflict graph. Now, if this particular graph has any cycle, we go to the view serializability to check if this schedule is a serializable schedule or not. If there is no cycle, we can say that this is a serializable schedule. If there is a cycle, we go to the view serializability and check for some conditions for a view equivalent. If all these conditions are met, we say that this particular schedule is a serializable schedule. If not, we say that this particular schedule is not serializable. Now, all these things may be sounding confusing to you, but don't worry, we would be talking about each and everything in depth in next set of lectures. For now, you can only think that view serializable schedule is a schedule which is view serializable. So a schedule is view serializable if its view equivalent is equal to a serial schedule execution. So whenever a schedule is view serializable, its view equivalent is equal to a serial schedule or serial execution. So whenever there is a serial execution of a view equivalent which we have found out for a schedule, we call it as a view serializable schedule. So coming to the next schedule, that is recoverable schedule. So a recoverable schedule ensures that if transaction reads data from another transaction, it should not commit until the transaction from which it read has committed. So consider if there are two transactions T1 and T2, and T2 is reading some data which is updated by T1. So T2 shouldn't commit until the time T1 commits. So T2 should always wait for T1 to commit, only then T2 should commit. If it commits before, and what if at some point this transaction fails, this particular operation will read some invalid data, because as T1 failed, there was a rollback and this particular operation is nullified now. So this data is invalid. So we have to wait for the transaction from which we are reading the data to be committed so that we commit the correct, or you can say the consistent data. So this helps in maintaining the integrity of database in case a transaction fails. So if at any point T1 fails, we will be able to recover T2 because T2 hasn't committed all the changes into the database. It's present only in the transaction logs. Now coming to the sixth, that is irrecoverable schedule. An irrecoverable schedule allows a transaction to commit even if it has read a data from another uncommitted transaction. So if the transaction is uncommitted, it allows another transaction to commit the data. This can lead to inconsistency and make it impossible to recover from certain failures. So what if transaction T1 fails at some point and we have committed the data based on what we have read from the updated value of T1, which is not updated into the database because the transaction has failed. So this will have a invalid data, and that particular invalid data would be committed or changed into the database. So it will cause inconsistency in the database because we are updating some invalid value or the value which is not consistent into our database. So the next schedule is cascading schedule. This schedule happens when the failure or abort of one of the transaction causes a series of other transactions to also abort. So consider if there are three transactions T1, T2 and T3. T1 has started its execution, T2 also started and T3 also started. At some point T1 failed. So here you can see that there was a write of A which was present in T1 and T2 read the same data which was updated as part of T1, but T1 failed. So this also needs to abort and this also needs to abort because we won't be updating any inconsistent value, or we won't be reading any inconsistent value which is not updated in our database. So there are multiple aborts which are happening. So here you can see T1 writes to A, so T1 writes a data item to A. T2 reads it, so T2 reads the uncommitted value of A which is written by T1. Now if T1 fails and aborts, T2 must also abort because it has read an uncommitted value which is from T1, and this particular value is also read by T3, so T3 also must abort. Now there are some issues. First is the performance degradation because multiple transaction needs to be rolled back. So there were some transaction which started, but because of one transaction failure, there are multiple rollbacks which is happening. So there is a performance issue. Second, improper CPU resource utilization because we use the CPU resources to perform these three transactions, but because of the failure of one transaction, all the transactions have to fail because they have read some uncommitted changes of that particular transaction. Now coming to the next schedule, that is cascadeless schedule. So it ensures transaction only read committed data such that the abort of one transaction does not lead to the abort of other transaction that have already read its uncommitted changes. So it makes sure that if any transaction is reading any value, it should always read a committed value. It shouldn't read a value which is not committed. When a transaction has already committed all its changes to the database, and if we are reading the committed changes, there is no issues which will occur here because these are all the changes which are saved into our database, and there is no chance of failure which occurs after commit because this is the final state. So this particular read operation won't have any inconsistent data. So T1 writes to A, T1 has written some value to A, and T2 reads from A. So T2 reads the committed value of A because it has been saved into the database, ensuring that there is no write-read problem which is happening. So in the cascading schedule, there was a write-read problem which was happening, but here it is not happening. And T2 does not read any uncommitted data because this data is committed. So there is no cascading aborts in this particular schedule. But here it says that one should only read committed data. But what about the write operation? So they haven't told anything about the write operation. They have only told about the read operation, that one should always read the committed data. But what if there is a write problem which can come, right? So there are some issues. First is the write problem is encountered because it has only told that it can read committed data, but not anything related to write operation. Second is performance overhead is there because again this needs to be committed. So this particular transaction can only read after it is committed. So it needs to wait for this to get committed. Coming to the last schedule, that is strict schedule. So it ensures that transaction is not allowed to read as well as write a data item that another transaction has written until the first transaction has either committed or aborted. So it makes sure that there is no read or write operation performed until that particular transaction from where we are reading or writing the data has been committed or aborted, basically has reached its final state. So it prevents the cascading aborts. So what will happen in T1 and T2? So T1 needs to complete all its operation, only then there could be any read as well as write operation which would be performed. So the write issue which was coming there, or write conflict which was coming there, is resolved now, because it can only write a data or it can only read a data once the transaction is committed. So T2 cannot read or write the value of A until T1 has committed. This ensures that T2 only sees the committed value of A. So this is how strict schedule prevents the cascading aborts and make the consistency at its peak. So I was getting so many queries on concurrent and parallel schedule. People were thinking that concurrent and parallel schedule are the same, but there are some differences between concurrent and parallel schedule. So let's learn about them. So first let's go through the definition. So concurrent scheduling manages multiple tasks at the same time. Tasks can overlap in their execution period but do not run exactly simultaneously. Consider if there are three transactions T1, T2 and T3. Now T1 can start at any instant T, T2 can start at any instant T dash, and T3 can start at any instant T double dash. So here you can see that all of these transactions, their execution may overlap, or you can say at the same time not all these three transactions are starting. But coming to parallel scheduling run multiple tasks simultaneously using multiple cores or processor. So in parallel schedule there are multiple cores, or you can say processor, which helps the transaction to run parallelly at the same instant of time. So all these three starts at instant of time T. So each task is executed on a separate core or processor at the same time. So all the three tasks are executed at the same time, while in concurrent schedule they can start at any instant of time. Now coming to the execution. So it is achieved on a single core processor through context switching, where the CPU rapidly alternates between the tasks, creating the illusion of simultaneous execution. So what happens when T1 starts and when T2 starts at any instant T dash, there is a context switching which happens between T1 and T2. Then again for T2 and T3 there is a context switching which which makes it as alternate, or you can say concurrent execution. But coming to parallel, it requires a multi-core processor or multiple processor, which each core handling a different task concurrently. So all these three cores will be handling different tasks, but they would be handling it concurrently. So all these three cores will run at the same time. They are running on the different cores, all the transaction, and each core will handle different set of tasks. Now coming to example. So consider an example where multi-threading on a single CPU core, where thread takes turns in the CPU. Now there are three threads, T1, T2 and T3. What will happen? They will not run on different processor or cores. They will only use this single CPU core. So first T1 will go and start its execution. Then there will be a context switch. Then T2 will go and start its execution. Then there will be a context switch. Then T3 will go and start its execution. So again there is a context switch which is happening between the threads, or you can say between the transaction, because they are utilizing the same CPU core. But coming to the parallel, multi-threading on a multi-core CPU, where threads can run concurrently on different cores. So consider if there are three cores and there are three threads. These three threads can run concurrently on different cores. So T1 can run on this particular C1, can run on C2 core, and T3 can run on C3 core. So they don't need to wait for their turns. They have the CPU core and they can go ahead and execute their thread there only. So this is the basic difference between concurrent and parallel schedule. So if someone asks you if concurrent and parallel schedule are the same, it's not the same. There are some differences between the concurrent as well as parallel schedule. Now, if you remember, in the schedule lecture, we learned about serial as well as concurrent schedule. Now, what are these? So, in serial schedule, all the transactions have a serial execution. In concurrent schedule, all the transactions have interleaved, or you can say alternate execution. Now, there were some advantages as well as disadvantages for serial as well as concurrent schedule. Now, coming to serial schedule, the advantage was it follows the ACID properties, so the consistency was maintained here. The disadvantages was there was very low throughput, like the number of transactions completing per unit time were very low. The wait time was very high, and coming to resource utilization, that was also very low. Now in concurrent schedule, the advantages was the throughput was very high, like number of transaction completing per unit time. The wait time was very low. The resource utilization was very high, but the consistency was low, or the consistency wasn't maintained. So because of multiple advantages, we use concurrent schedule everywhere. But there was one disadvantage, that was consistency. So it was not following the ACID properties. Because of this consistency, we introduced serializability and some concurrency control mechanism, which makes sure that even if the schedule is concurrent, it follows a serial execution. So serializability ensures that the concurrent transaction yield results that are consistent with some serial execution, that is the final state of the database after executing a set of transactions concurrently should be the same if the transaction had been executed one after another in some order. So serializability makes sure that if there is any concurrent schedule and if we are serializing that particular schedule, so S dash would be having a serial execution. So even if S dash is formed from a concurrent schedule, we make sure that S dash follows a serial execution so that the consistency is maintained. Now in case of concurrent schedule, consistency issue may arise because of non-serial execution, because of which we use the serializability concept. Now coming to serial schedule, we don't need to use serializability because the execution is already serial. Now in serializability, there are two types of serializability. First is conflict serializability and second is view serializability. So how do we know that this particular concurrent schedule is serializable or not? So first we need to check for conflict serializability followed by view. So in conflict serializability, we check that if there is any cycle which is detected in a conflict graph. If a cycle is detected, we go to the view serializability and we check that if the view equivalent follows some condition. If it is followed, we say it is serializable. If it is not followed, we say it's not serializable. If the cycle is detected, we go to the view serializability. If the cycle is not detected, we say that this particular schedule is serializable. So we first need to check for conflict serializability. If no cycle is formed, we can say that that particular schedule is a serializable schedule or that particular schedule is a conflict serializable schedule. If the cycle is detected, we need to check for view serializability, and if in the view serializability also some conflicts arises or if the condition is not met, we can say that that particular schedule can never be serializable or can never have a serial execution. Now how do we form the conflict graph? So conflict graph is basically formed on the basis of nodes as well as edges. So how we form the graph? In the conflict graph, the nodes is represented as the transactions in the schedule and edges is represented as conflicts in the schedule, and we need to detect if the graph has a cycle or not. Now in a serial schedule, we don't need to form the conflict graph because there are no conflicts. If you see here, all the execution of transaction 1 is getting completed, only then transaction 2 is starting. So there will be no edges because edges represent the conflicts. But here if you see, there are no conflicts. So we can say that there won't be any conflict graph for a serial schedule. Now coming to the concurrent schedule. So here there are two transactions T1 and T2. So we need to represent it using the node. So it is T1 and T2. Now coming to the execution. So here if you see, it starts with T1, then there is a context switch, then there are some execution in T2, then again there is a context switch, and then again there is a execution in T1. So if we need to draw the conflict graph for this, we can see that there are two edges and there is a cycle which is detected in this particular graph. So T1 goes to T2 and then again T2 goes to T1. So there is a loop, or you can say cycle, which is detected in this particular graph. So a concurrent schedule does not always have a cycle. So it's not always possible that a concurrent schedule will be having a cycle. It can have a cycle, it can't have a cycle. If it has got a cycle, we need to see for the view serializability. If it doesn't have a cycle, we can say that it is conflict serializable, because of which it is serializable. So a concurrent schedule can be conflict serializable, meaning that it is equivalent to some serial schedule of transaction and its conflict graph does not have any cycles. So if there are no cycles, we can say it is conflict serializable, that is it is serializable. If there is any graph, we need to check for the view serializability. Now since a cycle is detected, we need to serialize them. So we use the serializability here. First we use the conflict serializability to detect the cycle using the conflict graph, and then we use the view serializability to check if the schedule is serializable after a cycle has been detected. So in this way we use the serializability concept. Now why do we need to serialize them? So to avoid the consistency issue which may arise because of non-serial execution. So in the non-serial execution, we can have some consistency issue and we don't want our transaction to be inconsistent, because of which we use the serializability concept. Apart from serializability, we also use some concurrency control mechanism, of which we will be talking in the next set of lectures. So coming to the types of serializability, there are two types of serializability, conflict and view. In conflict serializability, we check that if the conflict graph has any cycle or not. In view serializability, we check that if a view equivalent is following some conditions or not. We'll be learning about all these as well in the next set of lectures. So before starting, let's just re-revise some older concept. So what was serializability? Serializability is a property of a schedule where the outcome is equivalent to some serial execution of transaction. So why do we need serializability? So in concurrent schedule, there was a non-serial execution of transaction, because of which there was some consistency issues which were coming into our database. So to encounter this consistency issue, we had serializability as well as some concurrency control mechanism. Now, as part of serializability, we make sure that if there is a schedule which has concurrent executions, or you can say interleaved execution, we'll try to have a serial execution of that particular schedule so that we can use the concurrent schedule and can also encounter the consistency issues. Now, what is conflict serializability? A schedule is said to be conflict serializable when one of its conflict equivalent is serializable. So basically, if a schedule can be transformed into a serial schedule by swapping non-conflicting operations, then the schedule is conflict serializable. So when do we say a schedule is conflict serializable? So ideally there are two methods which we can use. First is, what we can do is we can swap the non-conflicting operations, that is the adjacent operations, and we can find a conflict equivalent schedule. Now for this conflict equivalent schedule, if there are no conflicting operations present after swapping all the non-conflicting operations, we can say it is conflict serializable. Second is using the precedence, or you can say the conflict graph. So in the conflict graph, we see that if the conflict graph has any cycle or not. If it has cycle, we can say it is not conflict serializable. If it doesn't have cycle, we can say it is conflict serializable. So let's learn about first the conflict equivalent, and then we will go to the precedence graph. So conflict equivalent. If a schedule S1 is formed after swapping adjacent non-conflicting operations or pair in a given schedule S, then S1 and S are conflict equivalent. So if there are two schedule S and S1 is formed after swapping the non-conflicting operation of S, then we can say that these particular schedules are conflict serializable. Now what are the conflict and non-conflict pairs? So conflict pair are read-write, write-read, write-write when performed on the same data item. What are non-conflict pair? So they are read-read when performed on the same data item, read-read when performed on the different data item, write-write when performed on the different data item. So let's see. So why these are non-conflict pair? Consider if I am reading a data item A, and then as part of another transaction I am reading the data item B. So there is no conflict, right? Because we are only reading the value, we are not reading any modified value, or we are not updating any value, we are only reading the value. So it will not cause any consistency issue, because of which it is called as non-conflicting. Coming to here, so we are again reading the same data item, but again it won't cause any conflict or consistency issue. Coming to here, so we are writing a data item A and we are writing a data item B. So we are writing into different data items as part of transaction T1 and T2. So these are also non-conflicting, because if I am writing to data item A and again I am reading to that particular data item only, this could be conflicting, but these are not conflicting. Now coming to this one, where in transaction T1 we are reading the data, and in transaction T2 we are writing the data, but the data items are different. Here we are reading from A and here we are writing in B. So again, if the data item are different, there is no conflict. If the data item is same, if only there is a write operation involved, there would be a conflict, else there would be no conflict. Now coming to the conflict pair, we are reading a data item A and then we are writing some value to that particular data item A. So there is a read-write conflict. Again, we are writing to data item A and then we are reading it. Consider after some time this particular transaction fails. So we are reading some invalid data, because if it fails, it will abort and roll back and it will come back to its original value. But here we have read the updated value. So it will have an invalid value. That is why it is a conflict pair. Now coming to write, where we are writing on the data item, again we are writing on the data item as part of transaction T2. These all pairs are the conflict pairs where we are performing any write operation in any of the transaction on the same data item. These are the non-conflict pair, because if we are performing these operations, there is no inconsistency issue which is encountered in our database. So how to achieve a conflict equivalent schedule? So when a schedule can be transformed into a serial schedule by swapping adjacent non non-conflicting operations. Conflict arises when two transactions assess the same data item and at least one of them is a write operation. So whenever one of them is a write operation, and if there is any operation which is getting performed on the same data, write operation, read operation, then we can say that there is a conflict which is arising. Now, why we are only swapping the non-conflict pairs and not the conflict ones? So if we swap the conflict pairs, the order of execution, if it was read of A, write of A, the result of values may change, as first we were reading A and then writing or modifying A, but now it will be writing into A and then reading the modified value. So consider this was before changing the conflicting operation, and this is after changing the conflicting operation. So it would be T1 of WA and T2 of RA. So here if the value of A was 10, it reads the value of A, so it would be 10. It's write the value of A, that would be considered A plus 10. So it is 20. Now here it is writing the value of A. So A would be A plus 10. So that is 20. And now it is reading the value of A, that is 20. So if you see that here the value of A while reading was 10, but here the value of A while reading is 20. So if we switch the conflicting pairs, there could be a chances of data inconsistency, because the result which we were getting earlier and the result which we are getting after is different. So the modified value result might change if we change the order of execution. So let's solve a question where we have to find the conflict equivalent for a given schedule S1. So this is the schedule. What we have to do is we have to find the non-conflicting pairs and we have to swap it. Then we have to see that again if there are any non-conflicting pairs, and then again we have to swap it until the time we don't get any non-conflicting pairs. So let's see. So here the read is happening on X. Here the write is happening on X and read is happening on X. So there is a same data item, so there is a write-read conflict. Coming to here, so there is a read in X and there is a read in Y. So these is non-conflicting operations. So we will just mark it like this, that these both are non-conflicting operation. Coming to here, so there is read in Y and then there is a write in Y. Coming to here, there is a write in Y and then there is a read in Y. So there is a read-write conflict. So first is find the adjacent non-conflicting pairs and do a swap. So we have found the adjacent non-conflicting pairs, so we have to swap them. So Rx will come here and Ry will come here. So after the swapping, we have got Rx, Wx, Ry, then Rx has come here, then Wy and Ry. Now again we need to see that if there are any non-conflicting pairs. So this is Rx, then there is Wx, then there is Ry, and then there is Rx. So this is again a non-conflicting pair. Now coming Rx, Wy, so this is also a non-conflicting pair. And coming here, so there is Ry. So for this pair we have already swapped, but here we haven't swapped. So we have to swap Rx here and Wy here. Since we are reading the X and we are writing on Y, so the data item are different, that is why it is a non-conflicting operation. So after swapping this, the schedule we get is Rx, Wx, Ry, and this is being swapped to here and this is being swapped to here. So it will be Wy, then here it will be Rx and Ry. Now let's see the schedule again. So it's Rx, Wx, Ry, Wy, Rx, Ry. So here you can see that write is happening on the Y data item and read is happening on the X data item. So there are no more conflicts which is left in this particular schedule. But what if there is a schedule and I found the view equivalent of that particular schedule, but there are still some conflicting pairs which is present in that schedule. So that particular schedule can't be a conflict equivalent schedule for a given schedule S1. And we can also say that it's not conflict serializable. Now this particular method we don't use very often, because if the schedule is very large, then there would be a lot of complexities. That is why we use the precedence graph method or the conflict graph method. Now how to check whether a schedule is conflict serializable or not? So conflict occurs when two operations from different transactions assess the same data item and at least one of them is a write operation. So we use the conflict graph and precedence graph here. So conflict graph or a precedence graph is a directed graph which is used to determine the conflict serializability. The nodes represent the transaction, the edges represent the conflicts between the transaction. So we will be drawing a conflict graph where the nodes will be representing the transaction, there will be a directed graph, and the edges would be representing the conflicts between those transactions. So let's see how we can draw the conflict graph. So conflict graph has node, edges and cycle. Now node, each transaction in the schedule is represented as node in graph. So if there are two transactions T1 and T2, we represent T1 and T2 as the node in the graph. Now coming to edges, an edge from transaction Tx to Ty denoted Tx, Ty is added if an operation of Tx conflicts with any operation of Ty. So if in Tx, or you can say T1, if there is any operation, consider read of A, which conflicts with some operation which is present in T2, then we represent the edges, or we can say we represent the conflicts. So Tx operation precedes Ty operation in the schedule. So Tx operation will always precede the Ty operation in the schedule. Now coming to the cycle detection. So schedule is conflict serializable if and only if the conflict graph is acyclic. That is, there is no cycle in the graph. If there are no cycles in the graph, it means that the schedule can be serialized without violating the order of conflicting operations. So if there are no cycles in the graph, we can say that that particular schedule is conflict serializable. That means that that particular schedule is serializable. But if there is any cycle, we have to go to the view serializability, which is another type of serializability. So let's see that how using the conflict graph or precedence graph we can tell that if a particular schedule is conflict serializable or not. So check if the given schedule is conflict serializable or not. So there are three transactions T1, T2 and T3, and there are some operations which is getting performed on data item A as well as data item B. So there are two data items and there are three transactions. So let's see. So the step one is we have to find the conflicts in the schedule. How we can find the conflict is, first, if we are seeing for any transaction T1, we have to look in T2 and T3 for any conflicts. If we are checking in T2, we have to look for T1 and T3 for any conflicts. And if we are looking for T3, we have to check for T2 and T1. Now what are the conflicts? So there could be a read-write conflict performed on the same data item. There could be a write-write conflict performed on the same data item. There could be a write-read conflict performed on the same data item. So if we are checking for any write operation in a given transaction, we have to check for write as well as read. And if we are checking for any read operation, we have to only check for write operation. So let's see. So the first operation is read of A. So we have to check that if in T2 or T3 there is any write of A. So let's see, in T3 there is. So there will be a read-write conflict where there would be a conflict between T1 and T3 on A. Now coming to the next operation, that is read on A. So let's see if there is any write of A. Yeah, it is present in T1. So there will be a read-write conflict of T2, T1 on A. And let's see in T3, yes, there is present. So there will be a read-write conflict on T2 and T3 on A. Now let's come to this data item, that is write of A. So let's see, is there any read of A as well as write of A? So is there any read of A present? No. Is there any write of A present? Yes, it's present. So we can say that there will be a WW conflict between T1 and T3. We are not checking for the older operations because them we have already discarded or we have already found out the conflicts. So we are only looking for the operation for which we haven't found out any conflicts. So there will be a write-write conflict which would be present between T1 and T3 on data item A. Now coming to this one, write of A. Is there any read of A or write of A present? No, it's not present. Now coming here, write of B. Is there any read of B or write of B present? Yes, it's present. So it would be T2 to T3, write-read conflict on B. Now coming here, read of B, there won't be any conflicts. So these are all the conflicts which we have found out in the schedule. Now the step 2 is we have to find the nodes. So the nodes are all the transaction T1, T2 and T3. So we have found out the nodes. Step 3 is we have to find the edges and the conflicts. So conflicts we have already figured out. Now we have to find the edges. So there is a read-write conflict which is happening on T1 and T3 on the data item A. So on T1 we are performing a read of A and on T3 we are performing a write of A. So here the value of A is getting updated, but there is a read which is getting performed before even updating the value. So there will be an edge from T1 to T3 because T1 reads A before T3 writes A. Now there would be an edge from T2 to T3 because of read-write conflict. There will be an edge from T1 to T3 because of write-write conflict, T2 to T3 because of read-write conflict, and T2 to T1 because of read-write conflict. So here you can see that some of the edges are getting repeated, T2, T3, T2, T3. So we don't need to write for the repeated edges, so we can just discard one and we can only use one of the edge. And here also there is T1, T3 which is getting repeated twice, so we can only use one edge because we have already identified that there is a conflict. So there will be only 3 edges, T1 to T3, T2 to T3 and T2 to T1. So now we have to draw the graph. So first we'll draw all the nodes, so that is T1, T2 and T3. Now we have to form the edges. So there is an edge from T2 to T1. So this is the edge. There is an edge from T1 to T3. So this is the edge. And there is an edge from T2 to T3. This is the edge. So these are all the edges. But can you see that if there is any cycle formed or not? So there is no cycle formed. So since the graph has no cycles, we can say that this particular graph is conflict serializable. So in the step 5, we say the same. If the graph has cycle, it is not conflict serializable or serializable. If not, let's find the serial execution of transaction. So since it has no cycle, it is conflict serializable, means it is serializable. So if a graph is serializable, or if we can say a schedule is serializable, then we can find the serial execution, that how the serial execution will happen, or which particular transaction will start first and followed by others. So let's see. So let's find the serial execution of transaction. So we have to find the possible combination first. So there are 3 transactions. I told that the number of possible schedule when there are 3 transactions is 3 factorial, or whenever there is n transaction, that is n factorial. So 3 factorial is 3 into 2, that is 6. So these are all the possible combination where first T1 comes and then T2 T3, then T2 comes, then T1 T3, then T3 comes, then T2 T1. So these are all the possible 6 combination. So what we have to do is, we have drawn the graph. Now we have to find the in degree of the graph. So what is the in degree? In degree is the number of edges that is directed to that particular node. So we have to see that this is the node and how many edges are directed to this particular node. So if we see here, the in degree for T3 is 2. The in degree, there is no direction, so there is 0, and the in degree for T1 is 1 because there is 1 directed edge, here there is 2 directed edge, and here there is no directed edge. So we have found out for T1 it's 1, for T2 it's 0, and for T3 it's 2. So once we find the in degree, we have to find that particular node where the in degree is 0. So that would be the first one in the serial execution. So in T2 the in degree is 0, that is the less conflicts are there in T2. So we would be having T2 as the first in the serial execution. Now we will remove T2 from this particular graph. Now here it is T1 and T3. So now the in degree for T3 is 1 and for T1 it's 0. So now it will be followed by T1 and then it will be followed by T3. So this is how we find the serial execution of a conflict serializable graph. So what we have to do is, first we have to draw the conflict graph. Then in the conflict graph, we have to check if there is a cycle or not. If there is a cycle, we can say that that is not conflict serializable. And if there are no cycles, we have to find the in degree for all the nodes which are present in the graph. Once we find the in degree, we have to check that which particular node is having 0 as the in degree. So that would be the first one in the serial execution. Then we have to discard that particular node from the graph, and then again we have to check the in degree of all the other transaction, and we have to follow the serial execution in that manner. So the one possible equivalent serial schedule is T2 followed by T1 followed by T3. So all the executions would be happening first for T2, then T1 and then T3. So let's see if it is helping us to make a serial schedule without any conflicts. So there is T1, T2 and T3. So first T2 operations would be executed. So that is read of A, write of B. So it would be read of A, write of B. Then coming to T1, so it would be read of A, write of A. And then coming to T3, so that would be write of A and read of B. So here we can see the adjacent conflicts which were present earlier are now gone. So this is a conflict equivalent of this particular schedule which is present here. Now, what was the need of this view serializability? So in concurrent schedule, there was a non-serial execution of all the transaction. Now, since there was a non-serial execution of transactions, there was some consistency issue which was lacking in this particular schedule. So just to encounter this consistency issue, we introduced this serializability concept. Now, in this serializability, it makes sure that this non-serial execution get converted into a serial execution. So we find an equivalent schedule in which there is a serial execution. Now there were 2 types of serializability. First was conflict serializability and second was view serializability. Now in conflict serializability, we draw a conflict graph, or you can say precedence graph, in which we see that if the graph has any cycle or not. If the graph doesn't have any cycle, we can say that that particular graph or that particular schedule is a conflict serializable schedule, which means that that particular schedule is serializable. Now coming to view equivalent schedule, so whenever in this conflict graph there is a cycle, so we don't know that if that particular schedule is serializable or not. So because of that reason, we go to view serializable schedule. Now in this view serializable schedule, we find a view equivalent, and in this view equivalent, we check for certain condition, and if these conditions are met, we say that this particular schedule is view serializable. That is why the schedule is serializable. But if these conditions are not met, then we say that view serializability is not there, because of which the schedule is not serializable. So serializability helps us to tell that if a given schedule is serializable or not, or can have a serial execution or not. So view serializability ensures that the database state seen by transaction in a concurrent schedule can be replaced by some serial execution of those transactions. Now whenever we find cycle in conflict graph, we don't know if our schedule is serializable or not. So we use the view serializability here. So whenever we find the cycle in the conflict equivalent graph, we go to the view serializability to check if the schedule is serializable or not. Now a schedule is view serializable if its view equivalent is equal to serial schedule or execution. So whenever the view equivalent of a given schedule is equal to having a serial execution, we say that this particular schedule is serializable. Now let's see the condition for a view equivalent schedule. So for a schedule to be view equivalent, it should follow the following condition. Now the very first condition is initial read values. So if there are two schedules S and S dash, and S dash is a view equivalent of this particular schedule S, then an initial read of both schedules must be identical. So for example, consider if there are two schedules S and S dash. If in a schedule S, transaction T1 does the initial read for the data item A, then in schedule S dash, transaction T1 should be only doing the initial read on the data item A. So if in schedule S, T1 is the first transaction which is reading the value of A, in schedule S dash, T1 should always be the first transaction which is reading the value of A. That is, if read of operation is being performed on any data item here, it should be performed on the same in the view equivalent schedule. Now coming to the second, that is updated read. So in a schedule S, if Ti is reading B, which is updated by Tj, then in S dash also Ti should be reading B, which is updated by Tj. So consider here there is a read operation which is happening on a given data item which is updated by another transaction. So consider here read of B is happening and here T2 is updating the value of B. So T2 is updating the value of B and then the read of B is happening in T3. So the same should be happening in the other schedule, or you can say the view equivalent schedule. So here if you see, T2 is writing the value of B and here then T3 is reading the value of B. So whenever there is a read-write operation happening, they should be same in both the schedules so that there is no consistency issue which is arised. So if there is any update which is happening on any data item and after that there is a read getting performed, so the execution of transaction in which they are getting performed should be same in both the schedule S and S dash, where S dash is the view equivalent of S. Now coming to the third, that is final update. So a final write must be identical in both the schedules. If in schedule S, transaction Ti is the last to update A, then in schedule S dash, the final write operation on A should be performed by Ti. It's kind of similar to the initial read condition. In initial read, we say that if transaction T1 does the initial read of A, then in S dash also transaction T1 should be doing the initial read of A. That is, if there is a schedule S and if there is a view equivalent schedule S dash, there should be same initial read which is done by same transaction. Now here also it says that if there is a final write which is getting performed in any of the transaction T1, T2 and T3 on a data item X, so the same transaction should be performing that in the view equivalent schedule. So consider if the final write here is happening on data item A which is getting performed on T3. So here also the final write should happen on the data item A and it should be performed by T3. So this should be identical. So there are these three conditions which should be followed. First is initial read, second is updated read, and third is final write. So when these three conditions are met, we can say that this particular schedule or S dash is a view equivalent of S. So here is a question where we have to find the view equivalent of a given schedule. So this is a schedule S and we have to find the view equivalent of this particular schedule. One is we have to find if it is conflict serializable or not. So we have to find if this given schedule S is conflict serializable or not. So we will be drawing the conflict graph, and in this conflict graph first we will be drawing the nodes. So the nodes are all the transaction which is present. So it would be T1, T2 and T3. Then we would be drawing the edges. So edges represent the conflicts. So let's find the conflict. So conflict is always read write, write read and write write when performed on the same data item. And here you can see that there is the same data item on A, it is getting performed. So let's see if there are any read write, write write or write read conflicts. So let's see. So first is read of A. Is there any write of A present in any of the transaction? Yes, it's present in T2 and T3. So we'll just discard this and we'll just draw a line from T2 and then from T3. So let's go to the second, that is write of A. Is there any read of A or write of A present in any of the transaction? Yes, it's present in T1 and T3. Draw an H from T1 to T2 and then T1 to T3. Now coming to T2. So there is a W of A, that is write of A. Is there any read of A or write of A getting performed? Yes, it is getting performed in T1 and T3. So from T2 there would be a line to T1 and then from T2 there would be a H to T3. Now coming to T1. Write of A. So is there any read of A or write of A getting performed? Yes, there is a write of A. So T1 to T3 there would be an H, but it is already drawn, so we won't be drawing it again. Now coming to T3 there is a write of A, but is there any conflicting operation? No. All these values are already discarded, so there are no conflicting operation. So here you can see that from T1 to T2 and then T2 to T1 there is a loop which is being formed, or you can say cycle is being formed. So we can say that this particular schedule is not conflict serializable. Now we will be checking for view serializability. So this step 2 is find the possible number of serial schedules. So how we can find it? That is n factorial. So here the transaction are 1, 2 and 3. So it would be 3 factorial. So what could be the possible combination? So T1 goes to T2 goes to T3. It can be one of the possible serial execution. Then T1 goes to T3 goes to T2. Then T2 goes to T3 goes to T1. Then T2 goes to T1 goes to T3. And then T3 goes to T2 goes to T1. And then T3 goes to T1 goes to T2. So 3 factorial is equal to 6. So here there are 6 possible serial execution. Let's pick up this particular serial execution and then we would be seeing that if the view equivalent schedule which is formed with this serial execution, that is T1 goes to T2 goes to T3, is equivalent to this particular schedule S. So this would be S dash. So there would be T1, there would be T2 and there would be T3. Now we want a serial execution. So first all the operations of the T1 would be completed, that is read of A and then write of A. Now coming to T2, there is only a write of A. Now coming to T3, there is a write of A. So let's go to all the condition which we told that if there are two schedule S and S dash, they needs to follow this condition for them to be view equivalent. So first one was initial read. So let's see what is the initial read which is happening in this particular transaction S. So here the initial read of A is happening on T1. So T1 is having the initial read in S. Now coming to S dash, T1 is again having the initial read on A. So we can say that the initial read is same in S and S dash. Coming to update read, so let's see that wherever the value of A is getting updated, who is reading the value of A next. So here you can see that the value of A is getting updated here also, but there are no reads which is present after that. And here also the value of A is getting updated in transaction T1, then T2, then T3, but there is no read of A happening. Since there is no read performed after the update, no need to check for the update read. Now coming to the third condition, that is final update. So let's see that what is the final transaction where the value of A is getting updated. So here if you see, T3 is the final transaction where the value of A is getting updated. Now coming to this particular S dash, T3 is again the final transaction where A value is getting updated. So we can say that the final update is happening on T3 in both the schedule S and S dash. So we can say that since the initial read is same, the final update is same, and update read is not valid here because there is no read happening after the update, we can say that S and S dash both are view equivalent. So if the view equivalent schedule matches the condition, it is view serializable. So we can say that this particular schedule S is view serializable because it view equivalent follows all the condition which is needed for a view equivalent schedule. So this is view serializable, and then we can say since it is view serializable, this particular schedule is serializable as well as it can follow a serial execution of transaction. So this is how we find the view equivalent of a given schedule. So before starting with concurrency control mechanism, let's learn about concurrency control. So what is concurrency control? It is a process of managing multiple user access and modification in data simultaneously in shared or multi-user database system. Now consider an example of IRCTC. Now in this IRCTC, at a given time, there are multiple users who are going ahead and booking ticket from themselves. Now here, since there are multiple users who are going ahead and booking ticket from themselves, we can call it a multi-user system. Now here this IRCTC database would be getting updated or modified by multiple users. So we can say that this particular database is a multi-user database or a shared database. So for managing this multiple users and multi-user database, IRCTC uses this concurrency control. So it uses the concurrency concurrency control so that it can manage multiple user access and modification in data simultaneously in a multi-user database system. Now how it helps? So the first one is data consistency. So it ensures that the data remains accurate and reliable despite concurrent access. So concurrency control makes sure data is consistent even if there are multiple users who are accessing the website or the database at the same time. Now coming to the second thing, that is isolation. So it maintains the isolation property of transaction so that the outcome of a transaction is not affected by other concurrently executing transaction. Now since there are multiple users who are doing transaction at the same time, so consider user 1 is doing transaction T1, user 2 is doing transaction T2 and user 3 is doing transaction T3. Now as part of this transaction we are doing some operations of read and write. As part of this transaction also we are doing some read write operation. As part of this transaction also we are doing some read write operation. So there should be a isolation which should be maintained between different transactions so that if there is any modification of data which is being made here, this particular transaction doesn't affect from this particular read and write operations which is happening in transaction T1. So there should be a isolation between these three transactions so that the operation of one transaction doesn't affect the operation of other transaction until or unless this particular transaction is committed. Now coming to the third pointer, that is serializability. So it ensures that the result of concurrent transaction is same as if the transaction has been executed serially. So in the concurrent schedule, or you can say in the concurrent transaction, there is a non-serial execution of transactions. So because of this non-serial execution, there is some consistency issues which arises in our database. So serializability makes sure that this particular non-serial execution is converted into a serial execution so that consistency issue is encountered so that our database follows the ACID properties. Now coming to concurrency control mechanism. So we had serializability using which we were telling that if a given schedule is serializable or not, and there were view serializability, conflict serializability which were helping us for the same. Then what was the need of this concurrency control mechanism? So as part of serializability we were only telling that if a given schedule is serializable or not, but as part of concurrency control mechanism we use some techniques to make that particular schedule as a serializable schedule. So here we are using techniques to make a schedule as serializable. Here we were only using techniques to tell if a given schedule is serializable or not. So concurrency control mechanism are techniques used in database management system to ensure that the transactions are executed concurrently without leading to any inconsistency in the database. So whenever there is a concurrent execution, or you can say non-serial execution, there are some consistency issues which arises in our databases. So concurrency control mechanism makes sure that this particular inconsistency is not happening in our databases. Now in serializability we check if a given schedule is serializable or not, but in concurrency control we use certain techniques to make a schedule serializable. So we use certain techniques to make this particular schedule as a serializable schedule. Now why this particular concurrency control mechanism is needed? So there are certain anomalies or there are certain conflicts which arises in our databases. So first is lost updates. So whenever two or more transactions update the same data simultaneously and one of the update might be lost. For example, if two users modify the same record at the same time, the changes made by one user could override the changes made by other. So consider that if there are two transactions T1 and T2, T1 is performing a write operation on A and T2 is again performing a write operation on A. T2 commits, so here the updated value of A is considered 10, here the updated value of A is considered 60. So here the value of A is committed at 60, but after this the T1 also commits, so final value of A updated in our database would be 10. So you can see that there are some inconsistency which is arising and the changes made by one user could be override by the changes made by other user. Now coming to the second, that is dirty reads. So whenever a transaction reads data that has been modified by another transaction but not yet committed, if the first transaction rollbacks, the other transaction will read invalid data. So consider if there are two transactions T1 and T2. As part of T1 I am doing a read of A and write of A. As part of T2 I am reading the updated value of A. So here I have read the updated value of A. So consider the value of A here was 10. After update the value of A was 20. So here the value of A which was read was 20. Now consider at some moment this particular transaction T1 fails. So it will go ahead and roll back all the values. It will go ahead and roll back the value of A to 10. But here the value of A was read as 20. Now this particular value becomes invalid. So that is why dirty reads happen. Now coming to the third one, that is uncommitted dependency, or you can say dirty writes. So when a transaction modifies data that has been read by another transaction, leading to inconsistency if one of the transaction rollbacks. It says that consider if there are three transactions T1, T2 and T3. As part of T1 I am doing an update on A, as part of T2 also I am doing an update on A, and as part of T3 I am doing a write on A. And consider that because of any reasons this particular transaction fails. So since this particular transaction has failed, it will roll back the value of A to its original value, but here we haven't read the value of A. So this particular transaction has done some modification in A, and after this modification has been done, this particular transaction is reading this value. Now this particular value is inconsistent because there has been a failure in T1. So because of the failure in T1, this particular value becomes invalid, and because of that this particular value always become invalid. So there is uncommitted dependency because the transaction haven't committed, and because of the transaction haven't committed, there are some inconsistency which arises in our database. Now coming to inconsistent retrievals, that is non-repeatable reads. So it happens when a transaction reads the same data multiple times and get different value each time because another transaction is modifying the data between the reads. So consider if there are two transactions T1 and T2. As part of T1 I am reading the value of A, as part of T2 I am modifying the value of A, and again as part of T1 I am reading the value of A. So the value of A which is read here and the value of A which is read here would be different. So here you can see that as part of only one transaction, if I am doing two read operations, I am getting modified data. So that leads to non-repeatable reads. Now coming to phantom reads. So it occurs when a transaction reads a set of rows that satisfy a condition, but another transaction inserts or deletes rows that affect the set before the first transaction complete. This results in first transaction reading different set of rows if it re-executes the query. Consider if there are two queries Q1 and Q2. As part of Q2 I am adding or inserting some rows in my DB. As part of Q2 I am reading the number of rows or fetching the number of rows. So if I do this Q2 operation once, I get 3 rows, and if this Q1 operation is also executed at the same time, it will go ahead and add one more row, and after consider 1 second only, if I am again doing this read operation, I'll get 4 rows. So you can see that there are different number of rows which I am getting because of the addition. If consider that this is not addition, this is deletion, and it goes ahead and deletes some of the rows. So first it was 3 rows, now it is 2 rows. So here you can see that there is some discrepancies in the number of rows which I am reading while doing the query. Now coming to the some common concurrency control mechanism. So the first one is log-based protocol. Now as part of this we would be learning about two-phase locking, strict two-phase locking and locking protocols. Coming to the next one, that is timestamp based protocols. So as part of this we would be learning about basic timestamp ordering and Thomas Wright's rule. The third one is optimistic concurrency control, that is OCC. Fourth one is multi-version concurrency control, that is MVCC. Now from semester and interview point of view, this log based and timestamp based protocols are important, so we would be learning about them in more depth. About optimistic and multi-version, we would be seeing about the definition and what they are exactly, but we won't be going in more depth. So here are some of the commonly used concurrency control mechanism. The first one is log-based protocol. The second one is timestamp-based protocols. The third one is optimistic concurrency control. And the fourth one is multi-version concurrency control. So let's start with log-based protocols. So before starting with log-based protocol, let's just revise some older concepts. So in concurrent schedule, there was a non-serial execution happening. And because of this non-serial execution, the consistency was very low. Now for this non-serial execution, we introduced the methods such as serializability and concurrency control mechanism. As part of serializability, we try to see that if a given schedule is serializable or not. As part of concurrency control mechanism, we make the schedule as serializable. So here is the first concurrency control mechanism, that is log-based protocol. So as the name suggests, we are using some kind of logs so that we can achieve serializability and so that we can make a schedule serializable. So here are some types of log. The first log is binary log. So it is a simple mechanism where a data item can either be logged or unlocked. If a thread tries to acquire the lock when it's already locked, it must wait until the lock is released by the thread currently holding it. So as part of binary lock, we can lock or unlock a given data item A. Now coming to the next log, that is shared and exclusive log. So in shared log, it allows multiple transactions to read a data item simultaneously but prevents any of them from modifying it. So whenever we want to perform a read operation on any data item, we can use a shared log, but we can't do any modification. Multiple transactions can hold shared log on the same data item at the same time. So since it is used for the read operation, and whenever there is a read happening in different transactions, there is no conflicts. So multiple transactions can hold a shared log on a same data item. Now coming to exclusive log. So it allows a transaction to both read and modify a data item. When an exclusive log is held by a transaction, no other transaction can read or modify the data item. So whenever we want to perform a read as well as write operation on a data item, we can use an exclusive log. Now whenever we are using an exclusive log in one of the transaction, in next transaction we can't use the exclusive log on the same data item because there might be some read as well as write conflicts. So in shared log we are using it for read purpose, and exclusive log we are using it for read as well as write purpose. So whenever there is a write operation involved, there might be some conflicts such as write read conflict, write write conflict, and read write conflict. So just to avoid all these conflicts, if there is one transaction which is acquiring a exclusive log, we don't provide exclusive log to the next transaction. So if there are two transactions T1 and T2, and T1 is having an exclusive log, when T1 unlocks that particular exclusive log, we can assign an exclusive log to T2 for the same data item. So when it is unlocked, we can go ahead and assign the log. But in shared log, if transaction T1 is having a shared log on a data item A, as part of T2 also we can assign a shared log on data item A, because there is a read operation, so there is no conflict. But here, since write operation is involved, there could be read read conflicts. So here you can see that there are two transactions T1 and T2. As part of T1, we are giving an exclusive log, we are performing a read operation on A, write operation on A, and then we are unlocking it. After that, we are providing a shared log on B. So here you can see that there are different data items. So if there are different data items, we don't need to wait for one particular exclusive log to unlock or release itself. We can provide any shared or exclusive log to different data item. It is only applicable when the data item is same. So whenever there is a same data item, we can say that there could be some conflicts, but when the data item are different, there won't be any conflicts. So here we have provided a shared log, we are reading the value of B, and then we are unlocking it. So when we unlock any log, we can go ahead and provide any shared or exclusive log in case of an exclusive log. So when a transaction acquires a shared log on a data item, other transaction can also acquire a shared log on the same data item. So if there are two transactions T1 and T2, and T1 is acquiring a shared log, as part of T2 we can again acquire a shared log, enabling concurrent reads. However, no transaction can acquire an exclusive log on the data item as long as one or more shared logs are held. So if there are two transactions T1 and T2, as part of T1, if I am giving a shared log on A, I can't provide any exclusive log on A as part of T2 until this particular log unlock itself, because again as part of exclusive log I am doing a read as well as write operation, and as part of shared log I am doing a read operation. So there could be a read write conflict which could occur. So there will be a RW conflict. Now, when a transaction acquires an exclusive log on the data item, it has full control over the item, meaning it can read and modify it. No other transaction can acquire a log on the same data item until its exclusive log has been released. So if there are two transactions T1 and T2, and if T1 is acquiring an exclusive log on A, T2 can't acquire an exclusive log on A until or unless this particular log is unlocked. So if there is an exclusive log involved, there won't be any shared log or exclusive log, and if there is a shared log, then there won't be any exclusive log. There can only be a shared log. So when there is a shared log, there can be only shared log, no exclusive log. When there is an exclusive log, there can't be any shared or exclusive logs. So shared log can be present in any number of transactions. For exclusive log, only one transaction should hold it at one time. So while shared and exclusive logs are vital for maintaining data integrity and consistency in concurrent environments, they can also introduce significant challenges in terms of performance, deadlocks, reduced concurrency, and system complexity. So although they are helping us to achieve serializability to some extent, but there are some issues such as deadlock, reduced concurrency, and system complexity. Now, what are the drawbacks of shared and exclusive lock? So the very first one is performance issue. Managing lock require additional CPU and memory resources. The process of acquiring, releasing and managing locks can introduce significant overhead. So here we are acquiring a lock of exclusive or shared, and then we are releasing that particular lock. So it can introduce some performance overhead, because of which the performance issues can arise in our CPU as well as in our memory. Now coming to the next pointer, that is concurrency issues. So exclusive lock prevent other transaction from accessing locked data item, which can significantly reduce concurrency. So in concurrency, what we say is, if there are two transactions T1 and T2, there could be some interleaved transaction which is happening. But if I am acquiring an exclusive lock on any one of the operation of the transaction, other transaction can't go ahead and access the same data item until or unless the lock is released. So coming to the next point, that is starvation. Some transaction may be delayed if higher priority transaction consistently acquire locks before them, leading to starvation where a transaction never gets to proceed. Consider if there are three transactions T1, T2 and T3. As part of T1, I am acquiring an exclusive lock. It is happening at time T. As part of T2, I am acquiring a shared lock. It is happening at time T dash. And as part of T3, again I am acquiring a shared lock, which is happening at point T double dash. So here you can see that we are acquiring locks in different transactions, but since in transaction T1 there is an exclusive lock and this lock isn't released yet, so there won't be any lock which would be acquired in T2 and T3, and they will wait for T1 to complete. Consider that T1 completes at time T double dash. There is an unlock happened at time T double dash, and here shared lock on A is being demanded. So it will go ahead and give that particular lock to T3. It will say that your wait time is over, now you can acquire a lock. But T2 was waiting from the long to get the lock for itself, but it is now again waiting because there are some more higher priority operations which are coming into picture. This is how starvation happens in transaction, when transaction may be delayed if higher priority transaction consistently acquire locks. Now coming to deadlocks. So shared and exclusive lock can lead to deadlocks, where two or more transaction hold locks that other transaction need. So there could be some deadlocks which could be formed, because consider if there are two transactions T1 and T2, where T1 is acquiring an exclusive lock on A. Now T2 comes in, acquire an exclusive lock on B. This could happen because the data item are different. Now again T1 wants an exclusive lock on B. So it needs to wait for T2 to get completed, and consider that T2 again want an exclusive lock on A. So it needs for T1 to get completed. So here you can see that there is a loop which is getting formed and none of the transaction is ever completing and they are waiting for themselves. So because of this, the deadlock issue happens. We'll be learning about deadlocks in more depth in next set of slides. Now coming to the next point, that is irrecoverable. So if transaction B commits after the lock is released based on a modified value in transaction A which fails after some time. So consider if there are two transactions T1 and T2. As part of T1, I am giving an exclusive lock on A. I am reading the value of A. I am modifying the value of A. And then I am unlocking A. As part of T2, again I am giving an exclusive lock on A. I am reading the value of A. And I am writing the value of A. And then I am unlocking it. Consider that this particular transaction T2 goes ahead and commit all the changes in the database. Now in the database all the changes have been committed and it has read the updated value here, and on basis of that updated value it has performed the write operation. But consider that at some point this particular transaction fails, because nowhere we have told that there would be unlock happening when the transaction has committed all the changes. We haven't said that. So there could be a chances that there is some failure which has happened at some point of this particular transaction. So it will roll back all the operation and all the changes which was done as part of this transaction, but this particular transaction has read the value which was modified as part of T1, but now T2 is having an invalid value and that is already updated in our database. So this particular transaction can be recovered, but this particular transaction can't be recovered. So there is irrecoverability. Now what is this deadlock? So it is a situation when two or more transactions wait for one another to give up the locks. So here you can see that there is a resource R1 which is assigned to a process P1. Now P1 is waiting for R2 and R2 is assigned to P2 which is waiting for R1. So here you can see that there is a loop which is getting formed because P1 is dependent on R2, R2 is dependent on P2, P2 is dependent on R1 and R1 is dependent on P1. So there is a loop and there is a deadlock which is getting formed. So we saw that in the shared and exclusive lock there were some drawbacks. So because of this we introduced the two-phase locking. Now what is this two-phase locking protocol? This protocol ensures serializability by dividing the execution of a transaction into two distinct phases. First one is a growing phase. A transaction can only acquire locks but cannot release any. This phase continues until the transaction has obtained all the lock it needs. And coming to the shrinking phase, so after the transaction releases its first lock, it can no longer acquire any new locks. During this phase the transaction releases all the locks. So there are two phases, growing phase and shrinking phase. In growing phase they can go ahead and acquire any kind of lock they want, and in shrinking phase they have to unlock all the locks and they can't acquire any lock. So because of which the transaction can achieve serializability and consistency in the given schedule. So let's see how it happens. So here are two transactions T1 and T2. As part of T1 we are acquiring an exclusive lock on A. So we can say that T1 is right now in a growing phase. So it is going in a growing phase, so there is a read of A, write of A happening. Now transaction T2 comes, but since T1 is right now in a growing phase and T2 is not in a growing phase, there won't be any locks which would be assigned to T2. It will wait for this one to have in a shrinking phase and unlock all the locks. Now coming to here, there is a shared lock acquired on B, there is a read on B. So till here there is a growing phase which is happening because all the operations of the transaction are only acquiring the locks. Now there is a unlock of A which is happening, which is for this exclusive lock, and then there is a unlock of B which is happening, which is for this particular shared lock. So this particular state we can call as shrinking phase, and this particular phase we can call as growing phase. So now there is a growing phase of T1 and then there is a shrinking phase of T1, and since the shrinking phase of T1 is achieved, we can go ahead and acquire a shared lock on A present here because right now it is unlocked. So you can see that when a transaction acquires a growing phase, it will go ahead and acquire locks in that particular growing phase. It won't go to another transaction and give any kind of locks until or unless there is a shrinking phase which has happened for all the locks which is present here, and then they can go ahead and give the shared lock or exclusive lock in another transaction which are waiting for them to get completed. So in this way we can achieve the serializability and consistency, because here you can see that first all the operation of transaction T1 is getting completed, only then the T2 one is starting. So T1 is getting completed first and then the T2 is starting, so there is a serializability which is achieved here. Now let's see the advantages and disadvantages of 2PL, that is two-phase locking. So first one is it guarantees that the schedule of transaction will be serializable, meaning the results of executing transaction concurrently will be the same way as they were executed in some serial order. So if there are two transactions T1 and T2 and there are some operation which is happening concurrently, consider read of A, write of A in T1, then there is a read of A in T2, then there is a read of B in T1, and then there is a write of B in T1. So as part of 2PL, there will be two phases, growing phase and shrinking phase. So first it will start with the growing phase. It will acquire an exclusive lock on A. There will be one more exclusive lock on B. So it will acquire all the locks in the growing phase. Now there will be a shrinking phase where it will unlock all the locks. So it will unlock A and it will unlock B. But since T2 has a read operation, it will wait for this particular exclusive lock to get released. Only then it can acquire a lock. So the shared lock on A in T2 will wait for this particular exclusive lock on A to get completed or get unlocked. Only then the transaction of T2 will start. So here you can see first the transaction of T1 is getting completed, then only T2 is getting started. So there is a serial execution which is established. So there is a serializability. Now by ensuring that the transaction are serializable, 2PL helps to maintain data integrity and consistency, which is critical in environments where data accuracy is essential. Now coming to disadvantages, deadlocks, starvation and cascading rollbacks are still there. So consider if there are three transactions T1, T2 and T3. As part of T1 we are acquiring an exclusive lock on A, as part of T2 we are acquiring an exclusive lock on A, and as part of T3 we are acquiring a shared lock on A. Now consider that this particular has come to its shrinking phase and there is an unlock which has happened. So this one was waiting for this unlock to happen so that it can acquire an exclusive lock, and this was waiting for this one to complete so that it can acquire a shared lock. Now consider at some moment of time this particular transaction fails. So it will go ahead and roll back this particular transaction, but since this and this transaction was dependent on the changes which was done as part of T1, so this will also go ahead and roll back and this will also go ahead and roll back. So there will be a cascading rollback which would be happening because one of the transaction has failed, another transaction had some dependency on this particular transaction T1. Now, transaction must wait for the locks to be released by other transaction. This can lead to increased waiting time and lower the system throughput. So here you can see that as part of T2, we wanted to do a read operation, but we need to wait for all the exclusive locks and shared locks which has been assigned in this transaction to get released, so that we can acquire any locks and we can proceed with our transaction. So here you can see that the waiting time is more. Now coming to the third one, in case of a system failure, recovering from a crash can be complex, because consider that if at some point this particular transaction failed and this particular transaction was dependent on some of the values which is present in this transaction, so we can't go ahead and roll back the committed changes which we have done as part of other transactions. So in shared and exclusive lock, there were a couple of disadvantages which is taken care in two-phase locking, like serializability is achieved here, concurrency is achieved here, data integrity is achieved here. But there were some disadvantages like irrecoverability, starvation, deadlocks, and cascading aborts, which is newly introduced, is still persisting here. So for this, we have a stricter version of 2PL, that is strict two-phase locking. So what is this strict two-phase locking? A stricter variant where exclusive locks are held until the transaction commits or aborts. So as part of exclusive lock, we do a read as well as write operation, and as part of shared lock, we only do a read operation. So what was happening is, consider in one transaction there is an exclusive lock which is present, there will be a write operation which would be present, and because of this write operation, if another transaction is reading anything which is modified here, and what if this fails, there will be an invalid update into our database. So because of which it says that the exclusive locks are held until the transaction commits or abort. So this particular transaction should commit or abort, only then the unlock of this particular exclusive lock would be happening, so that if there is any modification which is made as part of a transaction T1, T2 shouldn't read any invalid value. If it's a commit, it will go ahead and read the valid value which is present in the database. If this is a abort, it will go ahead and roll back to its original value. So at this case, there won't be any dirty read problems which would be happening. So this helps prevents cascading rollbacks, where one transaction rollback causes other transactions to roll back. So here we are only unlocking it or releasing the lock once the transaction is committed or aborted. So there won't be any cascading rollbacks which would be happening in different transactions, because there were no strict rules for any of the lock that when they can unlock themselves. But as part of strict 2PL, we says that if there is any exclusive lock, it would only unlock itself once it commits or abort its operation. So the advantages are, it prevents the cascading aborts. The second advantage is it ensures strict serializability. So there will be a strict serializability which would be ensured, because there won't be any invalid data which is getting updated in our database. So the consistency is more here. Now coming to the disadvantages. So since write locks are held until the end of transaction, other transaction may be blocked for extended periods. So since there is an exclusive lock which is happening in transaction T1, it will only unlock itself once it commit all the changes in the database. So there might be some time which should be taken by transaction T1 to commit all the changes. Till then, T2 would be waiting for a shared lock which needs to be acquired only when the T1 is unlocking the lock. So once T1 is unlocking the lock, only then T2 can acquire a shared lock. So the wait time will be more. Now coming to the next point, that is transaction may experience longer wait time to acquire the locks. So transaction may experience some longer wait time to acquire the locks. Now the third one is deadlocks and starvation is still there. So deadlock and starvation is still not encountered as part of strict 2PL, because again consider as part of T1 we are having an exclusive lock, as part of T2 we are having a shared lock, as part of T3 again we are having an exclusive lock, as part of T4 again we are having a shared locks. So these all locks needs to wait on each other to unlock, so that they can start their execution. So there still be deadlock which would be happening and a loop which would be happening, because all the other transactions are interdependent on each other for them to be unlocked. So here we can see that again there are some disadvantages which are still persisting. So there is one more stricter version of strict two-phase PL, that is rigorous two-phase PL. So what is this rigorous two-phase locking? So it is an even stricter version where all the locks, shared and exclusive, are held until the transaction commits. So 2PL, it says that the exclusive lock should only unlock themselves when they have committed or aborted the changes. But as part of rigorous 2PL, it says that exclusive lock as well as shared lock should commit or abort the changes, only then they can go ahead and unlock themselves. So the lock are held until the transaction commits or aborts. Now what are the advantages? Since all the locks are held until the end of transaction, the system can easily ensure that the transaction are serialized and can be recovered. So since there are locks which is getting held in both exclusive as well as shared lock, so there is a guarantee of serializability as well as recoverability. Now it prevents the cascading aborts and dirty reads. What are the disadvantages? So the performance bottlenecks are there. Increased transaction duration, because earlier they were only hold on the exclusive lock, but now the hold is present on the exclusive as well as shared lock until or unless they commit or abort. So there is an increased transaction duration. Third point is deadlock and starvation is there. So we can see that deadlock and starvation is something which is getting persisted for all the 2PL, two-phase locking, strict two-phase locking, rigorous two-phase locking. So again there is one more locking protocol, that is conservating two-phase locking. So conservative two-phase locking, or you can say static two-phase locking, is a variant of a standard two-phase protocol that aims to prevent deadlocks entirely by requiring a transaction to acquire all the lock it needs before it begins its execution. So what it says that all the transactions should acquire all the locks before even the transaction starts its execution. So if the transaction is unable to acquire all the required locks because some are already held by other transaction, it wait and retries. The transaction only starts execution once it has successfully acquired all the necessary locks. So once a given transaction has acquired all the locks which is needed as part of an operation which is present in the transaction, only then it will start its execution. Until or unless then it won't start its execution and it will wait. So consider if there are two transactions T1 and T2. As part of T1, we are doing a read operation on A, write operation on A. As part of T2, we are doing a read operation on B, write operation on B. As part of T1, again we are doing a read operation on A, write operation on A. As part of T2, we are doing a read operation on B and write operation on B. So before even the transaction start executing, it will acquire all the locks. So here it will need an exclusive lock on A. It will need an exclusive lock on B. So before the transaction start, it will acquire all the locks. So here T1 has acquired exclusive lock on A and exclusive lock on B. So since T1 has acquired the exclusive lock on A and exclusive lock on B, T2 can't go ahead and acquire any exclusive lock because T1 has already acquired all the locks which is needed for T2, and T2 can't start its execution even if one of the lock which is needed by T2 is not present, right? So first T1 will start all its execution, only then T2 can go ahead and acquire any locks and start its execution. So because of this, there won't be any deadlock scenario which would be present, because since a transaction never starts executing until it has all the lock it needs, deadlock cannot occur because no transaction will ever hold some locks and wait for other. So here T2 won't be holding any locks even though it requires an exclusive lock on A and exclusive lock on B. It needs to wait for this particular transaction to get completed. Only then T2 can go ahead and start its execution and acquire the lock. Here T2 has not even started its execution, then how it can go ahead and acquire a lock, right? So there won't be any deadlock situation which would be present here because T2 can't acquire any lock because all the locks have been acquired by T1 and it needs to wait for them. So in this scenario, deadlock cannot occur because neither T1 nor T2 starts its execution until it has all the lock it needs. Now coming to the next concurrency control technique, that is timestamp based protocol. So it assigns a unique timestamp. So whenever there are two transactions T1 and T2 and they start at any instant T, or you can say T dash, so it gives a unique timestamp to the transaction whenever they start its execution or their operations. So every transaction is assigned a unique timestamp when it enters the system. It is used to order the transaction based on their timestamp. So we can order the transaction that T1 started first, then T2 started, or we can also order their operation that read of A started of T1 first, then read of A of T2 started. So all these operation and all these transactions we can give a timestamp. So there are two important timestamps for each data item. First one is read timestamp, second one is write timestamp. So the last timestamp of any transaction that has successfully read the data item, that is RTS. So consider if there are two transactions T1 and T2. As part of T1, I am reading a value of A, writing a value of A. As part of T2, I am reading a value of A. So the last read operation on data item A happened on T2. So we can say that the last read operation happened in transaction T2 at particular timestamp T dash. So that is the RTS. Now coming to WTS, consider that it is doing a update on A and here also it is doing a update on A. So we can see that the last update on A has happened in T2 at timestamp, you can say T double dash. So WTS of this this is T double dash and RTS of this is T dash. So we give the latest of the read and the latest of the write timestamp. Now transaction with smaller timestamp are called as old transaction. Transaction with larger timestamp are called as young transaction, because consider that if there are two transactions T1 and T2, now T1 started at 7 p.m. and T2 started at 7:10 p.m. So we can say that this particular one would be having a larger timestamp and it would be having a smaller timestamp. So we can say that this particular transaction is an old transaction and this particular transaction is a young, or you can say a fresh transaction. Here are some rules for the timestamp based protocols which help us to tell that if there is a transaction, as part of that transaction, if there are any operation that should be executed or that should be rejected. So here is a RTS, that is read timestamp of A, WTS, that is write timestamp of A. So consider if the transactions are getting performed on a data item A. So first one is check the following condition whenever a transaction Ti issues a read operation. So whenever there is a read operation which is issued by a transaction Ti, what should be checked? So first one is the write timestamp of A should be greater than the timestamp of Ti, then the operation is rejected, that is rollback. If the write timestamp of A is less than or equal to the timestamp of Ti, then the operation is executed, and we set the read timestamp of A as the maximum of read timestamp of A and the timestamp of transaction Ti. Now coming to the second pointer, check the following condition when the transaction Ti issues a write operation. So the first one is if the transaction Ti is less than the read timestamp of A, then the operation is rejected, that is roll back the transaction Ti. If transaction of Ti is less than the write timestamp of A, then the operation is rejected and Ti is rolled back, otherwise the operation is executed, and we set the write timestamp of A to timestamp of Ti. Now again, I know that this particular rules would be sounding very confusing to you. You won't be even understanding that what is happening here. So I'll just give you a small trick which you can keep in mind so that you can know that if there are two transactions T1 and T2, then what all operations should be executed or rejected. So I told you about old and young transaction, how we distinguish between old and young transactions. So consider if there are two transactions T1 and T2, and if the timestamp of T1 is less than the timestamp of T2, we can say that T1 is an old transaction and T2 is a young transaction. Now consider if as part of T1 and T2 we are performing some operation. So since T1 is an old transaction, we assume that T1 should be completed first, only then T2 should be completed. So there would be a serial execution that T1 should be completed first, only then T2 should be completed. Now consider that as part of T1 I am doing some operations, and as part of T2 also I am doing some operations. So here there are no issues because T1 is getting completed first, only then T2 is getting completed. But consider if there is a use case where T2 operation is starting first, and then after T1 operation, either read operation or write operation is happening, although T2 started at a later point. So whenever the older one has done all the operations and then younger one has started its operation and older one is getting completed, there is no issues. But when the younger one has done all the operations and then older one comes ahead and does some of the operations, then there would be a rollback. So let's assume that there are two transactions T1 and T2. Suppose the transaction T1 has entered the system at 7 p.m. and transaction T2 has entered the system at 7:05. So T1 is the old transaction and T2 is the young transaction. Now then T1 has a higher priority, so it executes first and it enters the system first. So T1 will be executing first and then T2 would be executing. So it will be T1 goes to T2, that is a serial execution where T1 operations is completed and then T2 operation is getting completed. So how we can see that if there would be any rollbacks which would be happening? So if the younger one has done a read or write operation, so younger one has done a read or write operation and older one wants to do a read or write operation, then that is a rollback case. If younger one has done any read or write operation and older one wants to do any read or write, so there should be a rollback. So you can just remember in this way that if younger one is performing any operation and then the older one comes in and perform any of the operation, there should be a rollback. But if older one is performing any operation and then younger ones come, then there is a no rollback. So here you can see that there are two transactions T1 and T2. T1 is old, T2 is younger. So T1 is performing operation, T2 is performing operation, no issues. T1 is performing a write operation, T2 is performing a read read operation, no issues. T1 is performing a write operation, T2 is performing a write operation, no issues. Because we are expecting that T1 would be completed first as it has entered the system first, and on the basis of priority, T1 should be completed. So this is how this timestamp based protocol works. So you just need to remember that if the younger one does some transaction and after that the older one comes ahead and does some transaction, the younger should roll back. But if the older one is doing any transaction and after that the younger one is doing, there shouldn't be any rollback cases. So this is all about the concurrency control mechanism. Now the first question which comes in mind is that why do we even need to learn about this database recovery management? So it involves strategies and processes to restore a database to a consistent state after a failure or crash. So whenever there is a failure or crash, we need some methods or management so that we can recover our database. Now what are the types of database failure? So the first one is transaction failure. It occurs when a transaction cannot complete successfully due to logical errors, or you can say system issues like deadlocks. So whenever there are some logical errors or system issues like deadlocks, we can face some transaction failure which could happen in our databases. The second one is system failure. So it occurs when the entire system crashes due to a hardware or software failure leading to loss of in-memory data. We have seen at certain times our laptop get turned off automatically or our computer system get turned off automatically. So there could be a system failure which could happen in our laptops or in our computers which could lead to loss in memory of the data. So we need to recover from this particular failure. Now coming to the next failure, that is media failure. So it occurs when the physical storage, that is hard drive, is damaged, resulting in data loss or corruption. So whenever there is a failure in a physical storage, or you can say hard drives, it results in the corrupting of data, because of which there is a data loss. Now we need to recover from all these failures. So what are the recovery methods we can follow? So first let's see about the recovery phases. So the first phase is analysis phase. It identifies the point of failure and the transaction that were active at that time. So it will identify that at what point the failure happened and what were the transactions that were active at that particular instant of time. Now coming to the redo phase, so it reapplies the changes from the committed transaction to ensure that the database reflects all completed operations. So whenever there is a failure which has happened as part of a transaction, it goes ahead and roll back that particular transaction. So as part of rollback, it will go ahead and roll back all the operation which has happened as part of this particular transaction. So it reapplies all the changes from the committed transaction. As part of rollback, it will go ahead and reapply all the changes from the last committed transaction which was successful to ensure that the database reflect all the completed operation. Now the third phase is the undo phase. It reverts all the effects of incomplete transaction to maintain the consistency. So here in the rollback, we are rollbacking all the operations which needs to be performed as part of T1. So let's learn about the recovery techniques. The first one is backup and restore. So whenever we take the regular backups, we ensure that the data can be recovered to the last backup which has been taken. So full, incremental and differential backup are the common types of backup. Now the second one is logging. So we keep a record of all the transaction, that is transaction logs. The write ahead logging or WAL protocol ensures that the logs are written before any changes are applied to the database. So whenever there is a transaction happening, if it does any read or write operation, it is getting saved in our transaction logs, and once all the changes have been committed to the database, it goes ahead and delete the transaction log. But if the changes are not committed to the database, we have the transaction log, and using this we can recover our database. Now the third one is shadow paging. So what is shadow paging? It maintains two copies of the database pages. One is the updated one and the other remains unchanged until the transaction commits. So if there is one database D, it will make a copy of that particular database D dash, and in that particular database D dash we have all the last changes which were saved, and we'll be doing all the operations on D. Now D dash would be having all the changes which were saved at the last time. So even if there is any failure occurred at D, it can go ahead and recover all the data which has been lost as part of D's failure. So these are all the techniques which we oftenly follow whenever we have any failure in our databases. Now what is this query optimization and why do we even need it? So whenever we want to improve the efficiency of our query, make it execute faster and consume fewer resources, we use the query optimization techniques. So whenever we want to increase the efficiency of our query, make our query to execute faster and give results in faster time, and whenever we want to consume some fewer resources of our system, we use this query optimization technique. So consider if there is an employee table, and in that particular table we have some employee details such as employee ID, employee name, employee age, and much more fields. Now consider that this employee table has 1000 records. And in that 1000 record, I make a query that give me the details of employee whose employee ID is 990. So I want to fetch the detail of employee whose employee ID is 990. So it will go ahead and it will do a search on the employee ID and it will see row by row that wherever EID matches 990, it will return the entire result of this particular row. But this query may take some time. And consider that in real scenario, our employee table has 1 lakh or 10 lakh plus records, right? So for that, we need to make our queries to execute faster so that we can get the faster result. That is why we use the query optimization techniques. So optimizing SQL queries is essential for improving the performance of database application. So whenever we want to improve the performance of our database application, we need to optimize our SQL queries and we can use the query optimization techniques there. So let's see what are the common techniques which we use. So first one is use indexes efficiently. So index the column frequently used in where, join, order by, group by clauses to speed up the data retrieval. Now what is this indexing? Indexing is basically a technique in which we lower down the number of disk access which was being used earlier. So it lowered down the number of disk access, because of which the queries gives us the result in faster duration of time. For now, if you're not understanding indexing, don't worry, we'll be having a dedicated lecture on indexing and types of indexing. There the concepts would be clear. But for now, you can only understand that whenever we are doing any group by, where, order by clauses, it's better to use the indexed columns there to get the faster result. Now coming to the second point, that is select only necessary columns. So avoid using select star, especially only the columns you need in your query. This reduces the amount of data transferred and processed. So most of the cases we use the select star to fetch some of the details. But if we know that we have to fetch only some specific columns, it's better to provide the columns rather than providing a select star, which will go ahead and fetch all the details or all the attributes which is present for that particular employee or for that particular XYZ entity. So we should take care that if we want only specific columns, it's better to use that particular columns with the select statement rather than using the select star. Now coming to the third point, that is optimize join operations. So choose the right join type and use indexed columns in the join condition. Now what is join? So basically in join, what we do is consider if there are two tables A and B and I want some details from A as well as B table, I'll perform a join operation between them on the basis of a common entities, or you can say common attribute which is common between both the tables. Now it says that whenever you are performing the join operation, always take care that you choose the right join type. And second thing, if you are joining on basis of some column, always make sure that that particular column is an indexed column so that the number of disk access lower down and we can get the queries result faster. So we perform join whenever we want some related rows of different tables, and on the basis of parameter or on the basis of a related column on which we are joining, that should be indexed. Now coming to the fourth point, that is partitioning large tables. So for very large tables, consider partitioning them to improve the query performance. Partitioning allows the database management system to scan only relevant partition, reducing input-output cost and improving the response time. So it says that if your database is too big, so partition that into smaller chunks and then make a query on that smaller chunks so that you can get the result faster. It will reduce the input-output cost as well as the response time. Now coming to the fifth point, that is cache the results. So cache the results of frequently executed queries to avoid the redundant calculations. It says if there is any query which is getting executed as part of different API calls, so it's better to call a cache rather than calling a DB, because calling to the DB may take more time, but if the response is stored in the cache for consider X duration of time for the similar query, it's better to call the cache so that we can get the result faster and also we can avoid some redundant calculations. So let's learn about physical storage and file organization. So what is a storage device? For storing the data, there are different types of storage operations which is available. So storage device basically help us to store the data. Now what are all the options which are available? So first one is primary storage, second is secondary, and third one is tertiary. Now coming to primary storage. So it is basically the main memory and the cache memory. It is fastest, it is expensive, and as soon as the system leads to a power cut or crash, the data also gets lost. So data is only stored in the system until or unless there is a system crash or power failure. After that, the data is lost. Now coming to secondary storage, it consists of flash memory and magnetic disk storage, which is non-volatile. Non-volatile basically means that it saves the result even after there is a system crash, or you can say power failure. So it stores the data permanently, and this is volatile because it loses the data once there is a power failure or system crash. Now coming to the tertiary storage, so it basically involves optical disk and magnetic tape. It is used for data backup and storing large data offline. So whenever you want to store large data, you use this tertiary storage. Whenever you want to store the data permanently, you use this volatile, or you can say secondary storage. And whenever you want to store data for some duration, you can use this primary storage, although primary storage is the fastest, but it is also expensive. Now databases store data in files on disk. So there are some disk which is present. You can say hard disk. In that disk, there are some files in which the data is stored. So each table or index may correspond to one or more files. Each file has a sequence of record. So each file consists of some sequence of record. Now accessing data from RAM is much faster than accessing data from a hard disk or SSD. So what happens is there is a CPU which access some data from the hard disk or from the SSD. But CPU is very fast and this hard disk or SSD is very slow. So it's better that CPU don't make a direct query to the hard disk. It go to the RAM and RAM makes a query to the hard disk so that this particular process is streamlined. So here you can see this is because RAM is designed for high speed read and write operation. Data retrieval in RAM typically involve fetching data in nanoseconds. So in RAM you can fetch the data in nanoseconds. So CPU makes the queries to the RAM and RAM checks if it has the desired result. If it doesn't has, it goes to the hard disk, it takes the blocks and it does the query checks if it has the desired results or not. Now RAM provides fast volatile memory for quick data retrieval. So volatile here means that after a system crash or failure, the data will be lost. Now data is accessed via addressable location and cache memory enhances speed. So the cache memory enhances the speed and data retrieval is done based on the addressable location. Now what is hard disk? So it provides a slower non-volatile storage with mechanical components that impact the access speed. So since CPU can't do a access on the hard disk itself or can't do a query on the hard disk itself, it goes via RAM because RAM is very fast and hard disk is comparatively slow. So data retrieval involves moving the read-write head and waiting for the disk rotation. So data retrieval basically involves moving the read-write head and waiting for the disk rotation. Now, when a program or application needs to access data, it first checks if the data is available in the RAM. If the data is not available in the RAM, it must be loaded from a slower storage device like hard disk or SSD. Index file in database management system are stored on the disk but are also managed in RAM to optimize the performance. Let's see that when we give query, how we get our results back. So here the query is fetch the detail of the student whose roll number is equal to 5. So there is a student table which is present and I want to fetch the detail of a student whose roll number is 5. So how the query will be executing? So firstly, the student table would be present in the hard disk because hard disk is a non-volatile memory. So it will save the data even if there is a system crash or failure. So it will save the data permanently. So we'll store this particular table in the hard disk. Now inside the table there are multiple records. So we store this particular records in some blocks. So there are blocks like B1, B2, B3 till Bn. So there are a couple of blocks in our hard disk and in each block we store some data. Consider in this block we are storing from 1 to 5 roll number, then from 5 to 10, then from 10 to 15. In all these blocks we store all these particular records. Now what will happen once the CPU receives the query? It will make a call to the RAM. It will say that I want the detail of a student whose roll number is 5. Now RAM will call the hard disk and hard disk will give all the blocks one by one, like first B1 is given, then B2, then B3, and in this blocks it will search that if there is any student with roll number 5 existing. Once it finds the student with roll number 5 existing, it will take up all the details and it will give it back to the CPU and then we can get the desired result. So this is how it functions. We use the RAM because the access is very fast and this is a volatile memory, so it won't be staying so long, like after the system failure or a switch. This is how the query execution happens. Whenever we give a query, it goes to the CPU. Now CPU makes the call to the RAM makes the call to the hard disk. Each and every block is transferred one by one and it checks in the block that if the query satisfies. When it checks that if the query has satisfied, it gives away the processed result. So how files is organized? So here you can see that there is a hard disk and there is a DB, or you can say table. Now in this hard disk there would be multiple blocks B1, B2, B3 till Bn. Now in this particular block B1, how much data of this particular table could be stored? How we can find that? So files are basically allocated on the hard disk in a contiguous blocks to reduce the fragmentation. Now number of records stored in each block is equal to size of block divided by the size of. So consider if there are 10 records here and size of each block is 100. So what we will do is we'll do 100 divided by 10, that is size of block divided by size of record. So it is 10. So in each block we can store at least 10 records. So this is how we find that in each block how many records we can store. So records can be stored in two ways. First is sorted way, searching is fast. Second is unsorted way, where searching is slow and insertion is fast. So we can store the data in a sorted or unsorted manner. In sorted manner the searching will be fast. In unsorted manner the searching will be slow but the insertion would be fast. So this is how we can optimize our query and organize the files in our system. Now the very first question which would be coming to your mind is, why do we even need our indexing? So let's take an example of a textbook. So imagine you have a 1000-page textbook and you want to search for a specific topic XYZ. So you are having a book. In that particular book I ask you to search about a given topic XYZ. Now how you can do that? So first thing is, whenever we have the index or the contents of the book, we can go ahead and see that where that particular topic is present and we can go to the page number. Consider a case where you don't have the index which is present in the book. Now in that case what you will do is you will search each and every page one by one. Now there are 1000 pages in the book, so consider the time you would be consuming when you are searching for each and every page one by one. So here indexing comes into picture. So when the indexing is not present, you need to manually search for each term in the book, which could be frustrating and time consuming. Now the second case is, when the indexing is present, the index allows you to quickly locate each topic. You can look up for XYZ, find that which is page number where it is covered. This makes it more efficient and less time consuming. So you'll get a range of page numbers. In that particular page number range, you can just go ahead and search for that particular topic. Now here you can see that here you are hardly searching for 2 or 3 pages, but earlier you need to search for 1000 pages. So you can see the search space has also reduced and the time consumed is also reduced. So this is how indexing helps us. So indexing is a critical technique in database management system that significantly improves the performance of query operations by minimizing the number of disk access. Index table is always sorted. Now what does this mean, minimizing the number of disk access? So every data of us is present in our hard disk, or you can say in our disk. Now in this particular disk we have our database. Now in this particular database there are some tables. In that particular table there are some rows, there are some columns, and they are stored in the form of blocks B1, B2, B3, which I discussed in the last video. Now you need to go to each and every block to find a particular topic or a particular key. Now here you can see that when you have an indexing which is present, which says that if you want to search for XYZ, it's present in block B2. So you'll directly go to block B2 and just search for that particular topic or that particular key. Rather than going to each block one by one, you just need to go to one block. So you can see that it minimizes the number of disk access. So the number of disk we are accessing or the number of blocks we are accessing is very much minimized. Now why do we need indexing? So in the same way how we have used indexing in the book, it helps us to find specific records or data entries in a large table or large data set. So consider if you have a large data set in which consider you have 10,000 rows. Now in this 10,000 rows you don't need to go ahead and search for each and every row manually. Rather you can go to the index table and search for a specific key, and then pointing to that specific key you can go to the block pointer where that particular row is stored in the hard disk. So you can go to that particular block. So here you can see that you provide a search key and the data access in the index table. Now in the search key it is used to find the record, and data access, it contains the address where the data item is stored in the memory for the provided search key. So basically we have an index table in which we have a search key and the block pointers or the references to that particular data. Whenever we are searching for any key, it will come to this search key column. It will search for that particular key, then it will go to the block where that particular record is present, and then it will fetch that particular block in the memory. It will search for that particular value. Once it gets that, it will go ahead and send us in the final result. So the search key helps in finding what a user is looking for, and the data access tells us where the record is stored in the memory. It is basically a set of pointers holding the address of the blocks. So all these blocks have some address and that is stored in the index table. Now, how the indexing helps? So it helps in improving the query performance. Indexes allows the database management system to locate and retrieve data much more quickly than it could by scanning the entire table. So earlier what we were doing is we were scanning the entire table, or you can say entire blocks in which all the records are present. Now we only need to go to this index table, we need to search for that particular key which we are searching, and then we need to go to the pointing block where that particular value could be present, and then we only need to search for that particular block. So earlier we are searching for each and every block, now we only need to search for one or two blocks specifically. Now, indexes can be used to optimize queries that sort the data, that is order by, or group the data, that is group by. So as I told in the earlier slides, that index table is always sorted. So whenever we are putting any key which is present in this index table in the key column, they are always sorted. So this is a sorted data. So whenever we want a sorted data or a grouped data, we use index because that is very helpful. So whenever an index is available on the column being sorted or grouped, the DBMS can retrieve the data in the desired order directly from the index, eliminating the need for additional sorting operations. So earlier, whenever you want some sorted data based on some specific column, you need to perform some additional sort operations. But as the index table is always sorted, the key present in index table is always sorted, we can use this index table, or we can use the column on which this particular table is indexed, and that particular column, if we use with the order by and group by clause, it will help me to get my data more fastly and efficiently. Now we have certain indexing methods like dense indexing, where index entry is present for all the records, and sparse indexing, where the index entries are present only for a subset of records in the index. So let's learn about dense indexing and sparse indexing, like how we can store a particular key as well as their search pointers in our index table in different methods. So first one is sparse index. So sparse index is a type of database indexing technique where the index does not include an entry for every single record in the database. Instead, it contains entry only for some of the records, typically one entry per block. So consider that in our database we have some columns where ID is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what we are doing is from ID 1 to ID 3 we are storing in block B1. From ID 4 to ID 6 we are storing in block B2. From ID 7 to ID 10 we are storing in block B3. So what we are doing is we are only providing the first element of that particular block in our index table. So here in the index table I have stored all the first elements of different blocks, and whenever I want to search for a value, consider 3, I'll go to this particular index column, I'll see there is a 1 present, and then I'll go to here, I'll see that there is 4 present. So basically between 1 to 4, 3 would be lying, so 3 would be lying in this particular block. So it happens whenever our data is sorted. So whenever we have a sorted data, we can use the sparse index where we don't need to store the value or store the entry for each and every record which is present in our blocks. Rather, we can store only the first element of the block, and we can give the block pointer where that particular entry is stored in our database or in our disk. So if we need to provide entry for each and every row which is present in our block, it will make the index table a much more bigger table, and then again we need to go through each and every entry, and then only we can search for that particular data. So it will also take more time than the sparse index. In dense index we does the same, we include the entry of each and every record which is present in our table in the indexing table. So in sparse index we only give or provide the entry for, you can say, some specific or single record which is present in each block pointer, so you can say a subset of records. But in dense index we need to provide an entry for each and every record which is present in our database table or the table which is present in our hard disk. Now which have an entry for every record. So dense index have an entry for every record, sparse index have an entry for only single records of each particular blocks, or you can say it contains entry for only some of the records. Now it is used when we have an ordered data set. So whenever we have an ordered or sorted data set, we only use this particular sparse index. If the data set is not ordered, how can I say that I'll give 1 and 4, and if I want to find 3 I can go to this particular block, right? Because the data is not sorted. So when the data is not sorted we don't use sparse index, but when the data is sorted or ordered we use the sparse index. So if a table has 1000 rows and it is divided into 100 blocks, you can create a sparse index. The index might have only 100 entries, with each entry pointing to the first record in the block. Now it says that consider our table is having 1000 records. Now these particular 1000 records needs to be stored in the hard disk. So how it will be stored? It will be stored in each and every block. Now consider here it is given that our hard disk has 100 blocks. So how many entries would be there per block? That is number of records divided by number of blocks. So we can say that there will be 10 entries which will be stored in each particular block. Now here we can see that in each block there would be 10 entries stored till 100 blocks. So there are 100 blocks which is present in our hard disk. So there will be 100 entries which would be made in this particular index table, and it would be having the entry for each of the first element which is present in the block. So there will be 100 entries which would be present in our index table. So you can say that each entry will point to the first record in each block. Now let's understand from this particular example that how the sparse indexing happens. So consider that this is my student table. Now in this particular student table, I have the student roll number and I have the student name. So the roll number is in a sorted manner 1, 2, 3, 4, 5, 6, and we have provided the names for all the students. Now what will happen that this particular table needs to be stored in the hard disk. So it will go ahead and store in the particular blocks which is present in the hard disk. Now in the block B1 we have 1, 2, 3. In the block B2 we have 4, 5 and 6. So per block we have 3 records which is stored in this particular hard disk. So how we can create the index table? So what we will do is first we will choose roll number as the index column. So we have choose roll number as the index column. Now we need to provide the search key, that is basically the roll number which is present here. So in sparse index what we do is we don't go ahead and provide the entry for each and every row which is present in our table. What we do is we choose the first element of the block and then we go ahead and provide the entry for that first element. So first entry would be 1 and then we will choose the first entry which is present in block B2, so that would be 4. So we have provided the roll number as the search key and here we have provided 1 and 4. Now we need to provide the access or the data reference where that particular data is stored. So we'll provide the block B1 here as from 1 to 3 all the data is stored in block B1, and then here we will provide block B2 as from 4 to 6 all the entries present in block B2. So this is how we create the sparse index. So how many entries could be there in the sparse index? So it is equal to the number of blocks which is present. So here you can see that there are 2 blocks which are present, so there are 2 entries which is present in the sparse index table. If there were 10 blocks present, there would be 10 entries which would be present in my sparse index table. So it is equal to the number of blocks the hard disk is having. So how sparse indexing actually works? So first is primary index. Sparse indexes are oftenly used with the primary index where the table is sorted on the indexed column. The sparse index only includes an entry for the first record of each block or page. So it only includes the entry for the first row of each block and page, and it is usually done on the primary key of that particular table, so that whenever we index the primary key, that will be always sorted and we can easily find any data value which we are searching for. Now the second thing is searching. So when the searching for a specific value, the database uses the sparse index to quickly locate the block where the record might reside. It then searches within the block to find the exact record. So how searching in the index table happens is, consider I want to search for an entry where the roll number is 3. So I want the details of the student whose roll number is 3. So what it will do is, it will first come to the index table. So it will go to the index table or the sparse index which is present. It will quickly locate the block where we can find 3. So here the search key is 1, here the search key is 4. So 3 would be lying in this particular search key. So we'll go to block B1. We'll go to block B1 here. We will pick that particular block and have it in our memory. And in our memory, we will go and search for this particular block B1 one by one. So there is 1, 2 and 3. Once we have got 3, we will take that and we will return that into our final result. So this is how the searching happens. So here you can see that we only need to search for one specific block. Earlier we were searching for different blocks. So the time complexity has also decreased. So although sparse index is helping us to execute our queries faster and get the results in faster duration of time, minimizing the disk access, there are some disadvantages which is present for the sparse index. Now what are these? So first is additional IO operations is involved. So after using the index to find the correct block, an additional search within the block is required to find the specific record. So when we are searching for a specific key, consider I am searching for roll number 3. If I am going to the index table, I am searching the index table. Wherever I am finding the search key, I am going to the data reference there, and then I am doing a search on the block which is present. So here you can see that there is an additional search which I need to do for that particular block. So because of this additional search, there is additional IO operations which is involved. Now the second thing is less efficient for random access. So if queries often need to retrieve random non-sequential record, a dense index might be more efficient. So whenever we want to do some searches in a set of data which is unordered, then we use the dense indexes. Sparse indexes can't be used there because sparse index generally works on an ordered set of data, because here we are only providing the entry for the first element which is present in our block, right? So here we can't provide any non-sequential or non-ordered data. So whenever we want to perform any retrieval on a non-sequential or non-ordered data, we use the dense index, because dense index has entry for each and every record which is present in these particular blocks or in this particular table. So in that case, we can do any random access for a particular data item. So coming to the use cases, primary indexing on large tables. So whenever we want to perform any primary indexing on large tables where the data is mostly sequentially stored, we can use the sparse index, because the sparse index helps us to fetch our queries in lesser duration of time rather than going to each and every block one by one and searching for data. It's better to go to the index table of the sparse index and then search for the data and go to the pointer and fetch that particular value. So now second one is range queries. So sparse indexes can be effected for a range queries where the query needs to retrieve a range of records rather than a single record. So consider if you want to search for a specific range of record, consider you want all the values or all the roll numbers between roll number 1 to roll number 6. So what you can do is, whenever you are performing any range queries, you can use sparse index, because here you only need to go to 2 rows or you need to only do 2 search operations, right? So here you can see that how fastly you can get a group of data or a range of data when you are using the sparse index. Now coming to dense index. So a dense index is a type of indexing technique used in databases where there is an index entry for each and every record which is present in our data file. This means that the index contains all the search keys and corresponding pointers or addresses to the actual data records, making it highly efficient for direct lookup. So whenever you want to search for any random value in a non-ordered data, you can just go to the dense index, because dense index has entry for each and every record which is present in the table. So you can just do a direct lookup from there. So it is used when we have an unordered data set. So whenever you want to make an indexing in a non-primary key column where the values are also not unique, the data is also unordered, you can use the dense index. Now consider a table with 1000 rows. Now you create a dense index on a non-primary key column, so it can have duplicate values. So the dense index will be having number of non-key unique records, each pointing to a specific row in a table. So consider that there is a non-key column on which you are providing the dense index, and it has some repetitive values, 18, 18, 18, 19, 19, 20, 20. So in the dense index, the number of entries would be equal to number of unique non-key records. So all the number of unique non-key records would be having an entry in the dense index table. So this is how the entries would be made when there is duplicate data set which is present. These are often useful in scenarios where random access to individual records is quite frequent. So whenever we want to do a random access to individual records, we can use this dense index. So here you can see that again we have the student table, and now we are providing indexing on the basis of column, that is age. So since age is a non-primary key column, we can expect some duplicate values which would be present in this particular age column, and here are the names of all the students. So now all these particular data are present in the hard disk, so it will be divided into the blocks. So each block would be having 3 rows. So B1 would be having 18, 18, 19, and then B2 would be having 20, 20, 21. So all 3 records are placed in one block, and these 3 records are placed in another block. Now how we will make the index table? So as I told, that index table would be having entries equal to the number of unique non-key columns. So here are the unique values: 18, then 19, then 20 and 21. So the search key or the indexed column on which we are making the indexing, that is age, would be having 18, 19, 20 and 21, and then we will provide the block pointer. So first search key is 18. So where 18 is present here, 18 is present here, and only block B1. So we'll provide B1 for 18. Now coming to 19, so 19 is present in block B1. So again we'll be given block B1. Then 20 is present in block B2 2 times. So we can provide B2 here. And then 21, which is present in block B2. So we'll provide B2 here. So here you can see that the number of entries which is present in the dense index is equal to number of blocks unique non-key records. So unique non-key records are present in this search key in the dense index table. Now how a dense indexing works? So in a dense index, each index entry includes, first is the search key, the value of the indexed column. The second one is a pointer or address to the actual record in the data file. So where this particular actual record is stored, this particular pointer tells us. Now when a query searches for a specific value, the database uses the dense index to quickly locate the corresponding record. Now consider I want the details of all the students whose age is equal to 18. Now although age is a non-primary key attribute, but since we have indexed index this particular column age, it will give me the faster results. So it will come to this particular index table, which is a dense index. It will search for 18. It has got 18. Now it will go to the block B1. It will go to the block B1. It will search in that particular block B1. Wherever it fetches 18, it will take that particular data and it will return that in the final result. So in this way, we can search for any random data which is present in our table using the dense indexing. Now, what are the disadvantages of dense indexing? So it requires significant storage space because it maintains an entry for every record in the table. So in sparse indexing, we were only storing the entry for each first element in the block, but here we are storing the entry for each record which is present in our table. Consider here also we are storing only for non-unique record, but again there are so many records which is getting stored here, right? So the storage is very intensive. Now coming to the next point, that is maintenance overhead is there. So inserting, updating or deleting records require updating the dense index, which can be costly in terms of performance, especially for large tables. So consider in this particular table, now Raghu has turned 20. So we have updated the value of Raghu's age to 20 here, but we need to update it that in the index table as well, because now it will be pointing to a wrong block pointer. Because of this, these particular operations are very expensive. So what are the use cases of dense indexing? First is primary indexing. Dense indexes are oftenly used for primary indexing when the table is small to medium size and quick access to individual records is required. So whenever we want a quick access to individual records, we can use this dense index because it has entry for each and every record which is present in our table. Now second one is exact matching queries. So it is ideal for the situation where the queries frequently request for individual records based on an exact key match. So whenever we want an exact key match that fetch the value of a person whose age is equal to 18. So whenever we were using sparse index, we used to provide the first element of the block, so we need to search for that particular block where the exact entry can happen. But in dense index, we can find the exact entry or exact record in the dense search key itself, so we can find the exact record very easily. Now whenever a query is run, the database engine checks the index to find the pointers to the row that contains desired data. It then retrieves these rows directly without scanning the entire table. So this is our index table. It goes ahead and searches in our index table. Once it searches in our index table, it goes to the block pointer where the data will be present. It fetches the data and it gives us the final result. Rather than going to each and every block one by one, we are reducing the block access which we are doing in our hard disk. Now how indexing works? So it takes a search key as an input and then returns a collection of all the matching records. So consider if I am searching for all the people who are having age 18, there could be multiple people who are having age as 18. So it will search for all the records where the age is 18 and it will return a collection of all the records. Now in index there are two columns. The first one is the one which stores a duplicate of key attribute or a non-key attribute, that is a search key. So search key can either be a key attribute or a non-key attribute in our given table. Now from the table, while the second one stores the pointer which holds the disk block address of the corresponding key value. So in corresponding to each and every search key, there are some block pointers which is stored. Now these particular block pointers point to the address that in our hard disk where this particular data for which we are searching is stored. So in the hard disk, all the data is stored in the form of blocks and we can provide the address of this particular block in this particular column. So we have learned about indexing. Let's learn about types of indexing. So there are mainly three types of indexing. First one is clustered index, second one is multi-level indexing, and third one is non-clustered index. Now in clustered index, we have two types of indexing. First one is primary indexing and second one is clustering indexing. Now when primary indexing happens, so when the key on which we are indexing is a primary key and the order of the data is sorted, we call it as primary index. It basically follows the sparse indexing methods. Now coming to clustering index, so when the key on which we are indexing is a non-key attribute, but the order or the data is sorted, we say that clustering index is present, and this we follow the dense indexing since there is a non-key attribute which is involved but the order is sorted. Now coming to the multi-level indexing. So whenever there is one more level of indexing in the index table, we use inner and outer indexes. So whenever our database is so large or so huge, the index table also becomes bombarded with entries. So we perform one more level of indexing there. We'll be learning about multi-level indexing in the next couple of slides. So it is mostly used for large files. Now coming to the non-clustered index, that is secondary index. So whenever the key is a non-key or a key attribute and the order is unsorted, so the data is not in a sorted manner and the key on which we are performing the indexing can be a non-key or key attribute, follow the secondary index there and we follow the dense indexing as an indexing method there. Now let's learn about each and every type in more depth. Distinguish the indexing based on the keys and non-key attribute. Now what they are exactly. exactly. So key attribute is a unique identifier for each record. It is oftenly used to distinguish one record from another. So whenever we want to distinguish one record from another record, consider if there are two records R1 and R2, there is an attribute which is present for R1 and R2 which can help me to distinguish between those two records. So that is called as key attribute. Now coming to the non-key attribute, so all the other data in the record besides the key, so all the other columns or all the other attributes beside the key attribute is called as non-key attribute. Now what is the single level indexing and multi-level indexing? So whenever there is only one index table involved, we can say that there is a single level of indexing present. But whenever there are multiple index table involved, like inner index, outer index, we can call as multi-level indexing. So single level indexing is straightforward and works well for a smaller databases, offering a direct approach to speeding up query performance. Whereas multi-level indexing is more complex but necessary for larger databases, as it effectively manages large indexes by creating an additional layer of indexing, thereby improving the data retrieval times. So here an additional layer of indexing is created in multi-level indexing because the databases is very large and have a lot of data which is present in that. So let's learn about primary index. It enhances the efficiency of retrieving records by using their primary key values. So here we use the primary key values of the given records. Now it establishes an index structure that associates primary key values with the disk block address. Now here this is the index structure where we provide the primary key of this particular table. Consider this is roll number, so roll number would be an indexed, and here we provide the pointers to that particular data where it is stored in this particular hard disk or in this particular blocks. Now this index is composed of a sorted list of primary key values with their corresponding disk block address. So this is a sorted data of the primary key values and their disk block address. Now thereby accelerating the data retrieval by reducing the search time. It is specially beneficial for queries based on primary keys. It is done on sorted data. So whenever our data is sorted and we have primary key which is present in our table, and whenever we want to index our primary key, we use this primary index. Now here you can see that there is a search key and the data reference, which is basically the data pointer to the block which is present here, and here we have a student table. Now in this particular student table, roll number is acting as a primary key, so this particular data would be fed in our hard disk. So this particular table will be present in our disk. For the first 3 records it will be stored in block B1, for the next 3 records it will be stored in block B2, and here we have provided the roll number, the name, and different set of data which is present in our disk. Now here whenever we are making the index table, as I told that whenever we are using the sparse index, we only provide the first element of the given block in our index search key. So here we are providing 1 for block B1, and here we are providing 4 for block B2. So here we have provided the address for that particular blocks. Now here sparse index, the number of records in the index file is equal to the number of blocks. So here we have 2 blocks, so there are 2 entries which are present in our index table. So this is our index table which creates an index structure that maps primary key values to the disk block address. So it maps the primary key values to their corresponding disk block address. Let's understand from an example. In a user table with user ID column as a primary key. So here user ID column is the primary key. A primary index on user ID can allow for quick retrieval of user records when you know the user ID. So whenever we know the user ID, we don't need to go ahead and search for each and every block for that particular user ID. Rather what we will do is we will go to the index table, and when we know the user ID, we'll search in the search key, and wherever we find the block pointer corresponding to that, we'll go to that particular block and bring that block in our memory and search for that particular values and get the details easily. So primary index ensures that the database can immediately locate the row associated with a given user ID, making operations like select, update, delete highly efficient. So it makes these operations like select, update, and delete when we know the user ID highly efficient. Now the next one in clustered index is clustering index. So clustering index is generally done on a non-key attribute. So whenever there is a non-key attribute as well as the data is sorted, we use the clustered index. So the data in the table is typically ordered according to the order defined by the cluster index. Mostly each index entry points directly to a row. It is mostly used whenever we are grouping the data. It is physically ordering the records in a table based on the index column. So what happens here is ki consider this is the column age, which is a non-key attribute, but the data which is present in our age is sorted. We can use this cluster index. Now in this particular non-key attribute, we can see that the data is sorted and age is a non-key attribute. Because of that, we can see that there are some duplicate data which is also present. Now this particular table will be present in a hard disk. So first 3 records would be present in block B1, and then the next 3 records will be present in block B2. Now here we have provided the age on which we are doing the indexing, which is a non-key attribute. So age here is 18, 18, 19, 20, 20, 21. Now here we'll be doing a dense indexing, because here we can see that the data is sorted, but there is a duplicate data as well as it is a non-key attribute. So we need to do a dense indexing here. Now in the dense indexing, what we will do is we will only provide the entry for the unique non-key attributes. We won't go ahead and provide entry for 18 two times, 19 one time, again 22 times. We'll only provide for the unique entry. So number of records in the index file will be equal to number of blocks of unique non-key records. So here we have gone to the search key. Here we have provided the entry for 18, then 19, then 20, and then 21. And here we have provided the block pointers for that particular data which is present in our hard disk. So whenever we want to search based on a non-key column, consider that I want the details of all my students whose age is 19. So what it will do is it will go to the index table. It will search for the search key 19. It has found the 19. Now it will go to the block pointer where it is present, that is B1. Now it will go to B1, it will search for the record 19, and then it will return either a single or the collection of data which is present in our hard disk, or you can say in our blocks. So let's understand from an example for a cluster index. So consider that there is an employee table. If you need to produce list of employees ordered by last name, creating a clustered index on last name can make the queries faster. So whenever there is a non-key attribute, there would be some duplication, and whenever we want to perform any group by operation or order by operation based on a non-key attribute, we can use this cluster index because it can make the queries run faster. Now cluster index keeps the rows in the last name order, reducing the need for the database to perform additional sorting when executing the queries. Now we have performed the indexing on the last name. So what it will do is it will order the last name which will be present in our index table. So we don't need to perform any additional sorting operations. We can use the index table and we can perform the group by or the order by clauses there. Now coming to the multi-level index. So multi-level index is an advanced indexing technique used in database management system to manage large indexes more efficiently. So whenever there are some large indexes or there are large data which is stored in our index table, we use this multi-level indexing. Now when a single level index becomes too large to fit into the memory, multi-level indexing help us in breaking down index into multiple levels. So it breaks down this particular index into multiple levels. So there is an outer index and there is an inner index which is present. So it reduces the number of disk IO operations needed to search through the index. What are the levels in the multi-level indexing? First one is the first level, that is primary index. The first level is the original index where each entry points to a block of data or a page in the table. So the first level consists of original index where each entry points to a block of data or page in the table. Now coming to the second level, that is secondary index. So if the first level index is too large to fit in the memory, a second level index is introduced or created. This index points to the block of first level index, effectively indexing the index itself. So consider that this is my index table. What will happen that there will be one more level of indexing which will happen. Now this particular index table will be having some of the entries of this particular index table, because here the data is sorted and there is a key attribute also present. So we'll be following a sparse index and some of the entries will be stored here. So here you can see that we are having an employee table. Now in this particular employee table, we have employee ID and the different data of that particular employee. Now here the employee IDs are given and corresponding blocks of them are given here. Now we make the index table. In that particular index table, we are indexing on the basis of EID. So we'll provide this EID in the index table and then we'll provide the pointer to that particular address where this data is stored. So we'll be providing the EID as E101, basically the first element of the block, and then we'll providing the block pointer. Now coming to this block, the first element is E151, so we'll provide B2 and E151. In the same way, we'll provide for all the entries which is present in these blocks. So here you can see that our index table is getting bombarded with a lot of entries, and here I have only considered some of the data. In real world there are lakh and crore of data, right? So what we will do is we'll create an outer index, and in this particular outer index what we will do is we'll group the data which is present in this index table, and then for that particular group we'll provide the EID and here the pointer to that particular group. So we have divided it into groups and we have provided the first element of the group, that is E101, then E201 and then E301. So for all these particular groups we have provided an entry, and here we have provided a pointer to that particular entry. So here you can see that we have introduced a new level of indexing and we have indexed the index table itself because the data was so large. So this is how the multi-level indexing works. Now coming to secondary indexing. So secondary indexing speeds up the searches for non-key columns in a database. Unlike primary indexing, which uses the primary key, secondary indexing focuses on other columns. So whenever we have other columns apart from primary key, we can use this secondary indexing. Now it creates an index that maps column values to location where the records are stored, making it faster to find specific records without scanning the entire table. Now in the secondary index, we basically work on the key as well as the non-key attribute, and the data is always unsorted. So whenever we want to work on a data which is unsorted and it can either be a key or non-key attribute, we use the secondary index. So the data is mostly unsorted and it can be performed on both key and non-key attributes. Now here key attribute doesn't only mean the primary key. There are multiple keys which are present in our table. Consider primary key, candidate key, super key. So don't ever consider that if there is a key attribute, it is always a primary key. It can be other attributes as well which is holding some unique values because of which we can find some data. Now the secondary index will be having two cases. The case one is when the search key is a key attribute and data is unsorted, and second is when the search key is a non-key attribute and the data is also unsorted. So let's learn about the first case when the search key is a key attribute and the data is unsorted. So here we have selected age, which is a non-key attribute, and the data is also unsorted. Here you can see 18, 20, then 45, 67, 68, then 22, 24, 30. So here the data is also unsorted and it is also a non-key attribute. So it is now stored in the blocks which is present in our hard disk. Let's understand it how the indexing will be done in this particular case. So here we can see that age is having an unsorted data, so we can use a dense index, and in this particular dense index, what we will do is we will provide an entry for each and every record which is present in our table. We have to just make sure that that entry should be unique. There shouldn't be duplicate entry which should be present in our index table. There should be only unique entries which should be present. So we'll go ahead and provide these particular entries in our index table. But the best thing about the index table is that the index table is always sorted. So it will go ahead and it will enter the data in a sorted manner. So search key will be present in a sorted manner, and then there will be a data reference or the block pointers to that particular search key. So here we have followed a dense indexing where the number of records in the index file is equal to number of blocks of unique key records which is present in this particular case. Now coming to the next case when the search key is non-key attribute and the data is unsorted. Now here age is a non-key attribute as well as the data is also unsorted. So here you can see what is happening. Age is 18, 18, then 20, then 67, then 22, then 22, 24 and 30. Here you can see that the data is also unsorted. There are some duplicate data and it is a non-key attribute. Now in this case how the indexing will happen. So here we can see that the 22 is happening in block pointer B1 as well as in B2. So how we will mention that in our index table. So what we will do is first we will provide the entry for each and every unique non-key record in our index table, and whenever we find that for a unique non-key record there is some entry which is present in B1, B2 or different blocks, what we will do is we will represent it in the form of a linked list. So what we will do is in the data reference column we will provide B1, and then the next occurrence of this particular 22 in this particular block, that is B2. So we'll provide it in a linked list manner or in a linked list fashion. So this is how we provide the search key which is always sorted in our index table, and this is how we provide the data reference. So here in the dense indexing, the number of records in the index file will be equal to the number of blocks of unique non-key records. Here we have discussed about almost all the types of cases when we have a key data but the data is unsorted, when we have a key data but the data is sorted, when we have a non-key data but the data is unsorted, when we have a non-key data but the data is sorted. So we have discussed on all these cases. Now we will be discussing on how we can create indexes in our databases. So how to create indexes. So we can create indexing based on one column or multiple columns. So let's see. First we'll see that how we can create non-cluster indexes, basically secondary indexes. So when we want to create on one column, so we give this command create index followed by a name which we provide to the index, and then we provide on, then the table on which we are creating the index, and then the column on which we are creating the index. So this is for one column. On multiple column we give the same command create index followed by index name, then on, table name, and then we provide the different columns in comma separated way. So this is how we create in non-clustered indexes. Now when we want to remove an index, we give this command drop index, then the index name, and then we provide on, and then we provide the table name. Now coming to the clustered index, so it automatically gets created with the primary key. MySQL does not support explicit creation of additional clustered indexes. So MySQL does not support any additional creation of clustered indexes. It automatically creates with the primary key itself. So before starting with B and B plus trees, let's just understand that why do we even need to learn about them. So clustered and non-clustered indexes are concepts that describe that how the data is stored and accessed in our database. So it tells us that how the data is stored and how we can access the data. But B trees and B plus trees are the data structure that actually implement these indexes. So the implementation of these indexes are done using B and B plus trees. So knowing B trees gives you insight into how these indexes work under the hood. So it helps us to tell about the implementation of these indexes. Now understanding B trees helps you to understand that why certain queries perform very well and poorly based on the structure of the index. So based on the structure of the index, we can determine that why a given query is performing very poor or very great. So for example, how a B tree or balanced nature affects search times, or why range queries are efficient with B tree indexes. So the balanced nature of B trees help us to get our data retrieval very fast, and it also helps us to search for the range queries. Now B trees provide the balanced, efficient structure that makes these type of indexes performant, ensuring that the operations like search, insert, delete and update are done in logarithmic time. So all the CRUD operations like create, read, update and delete are performed in logarithmic type whenever we use B tree data structures as part of our indexes implementation. So these makes B tree indexing crucial for optimizing database queries, whether in a clustered or non-clustered index scenario. So it really helps us to get all those CRUD operations performed in the logarithmic time, which is such a great time complexity, and we can get our data very fast. Now what is this B trees? So B trees is also called as a MV tree, where M defines the order of the tree. So we'll be learning about order of the tree in next set of slides. For now you can just understand that B tree also is called as MV tree, where M represents the order of the tree. So B tree are self-balancing tree data structure that maintains sorted data and allows searches, sequential access, insertion and deletion in logarithmic type. So all the CRUD operations are performed in a logarithmic time. Also all leaf nodes are at the same level in the B trees. So all the leaf node or the last node are at the same level in the B trees. Now in B tree you can minimum have 2 children and maximum x children, where x is the order of the given tree. Order is also represented using M, but here I am using x for reference. So x children. Now B tree is a generalization of a binary search tree. So if you don't know about binary search tree, I'll suggest you to go ahead and have a look on what is a binary search tree, because if you have a basic concept on binary search tree, B tree and B plus tree would be really easy to understand. Now in binary search tree, every node can have at most 2 children. That is, if this is a can either have 0 children, 1 children or 2 children. In the B trees we can have at max of x, or you can say m children, that is the order of the tree. Also here there would be only one key which would be present in each node, but here there could be multiple keys which is present in our nodes. Now let's learn about the structure of a B tree. So the first one is node. A B tree is composed of nodes, each containing keys and pointers to the child nodes. So this is a node which contains a key, as well as block pointers which references to the child nodes. So these are the child nodes and these are the block pointers which references to the child nodes. Along with the key we also have a data pointer. Now what is a data pointer? So data pointer or record pointer is the one where the record is present in the secondary memory. So data pointer or record pointer help us to know at what particular location our record is present in the secondary memory or the disk. Now the keys within a node are sorted in ascending order. So all the keys which are present within a node are sorted in ascending order. Now root, internal nodes and leaves. So the root node is the topmost node in the tree. So the topmost node in the tree is called as a root node. Now coming to the second one, that is internal nodes. So internal nodes contain keys and the child pointers. So these are the internal nodes after the root nodes, which contains the key as well as the child pointers, or you can say the block pointers. So these are the block pointers. Now coming to the third one, that is leaf node. So leaf node contains key and possibly pointers to the record of other data. So this leaf node also contains key and the block pointers, and these particular block pointers, when there are no further nodes, it points to the null. So these are the keys which are present here, and it points to the null. Along with the keys, we have a data pointer which tells us where the record is present in our secondary memory, or you can say disk. Now in indexing, each key in a B tree node typically represents a value or range of values, and associated pointer directs to a data block where the record is present corresponding to the key can be found. So for example, in a database, the key might be the value in a column and the pointer might be direct location to the row or a set of rows in a given table. So here we can see that all the nodes are having the same structure. They are having key, they are having the data pointer associated to the key, then they have a block pointer which corresponds to the address of their children's, and here it is the root node. After the root node, all the nodes are the internal nodes, and then at the last one we have the leaf node which also has key and data pointer. Now a B tree of order x can have the maximum number of children a B tree can have is x, that is the order of the tree. So the maximum number of children any node can have is the x, that is the order of the tree. Now coming to the maximum number of keys. So the maximum number of keys for every node is x minus 1. Now why it is x minus 1? So consider here the keys are provided k1 and k2, and here we have provided the block pointers. So at max I am saying that this particular tree can have only 3 children. So we'll have 3 block pointers, 1, 2 and 3, and here you can see that we have only provided 2 keys because there is 3 block pointers. So we can say the number of block pointer is the maximum number of children the key can have, or the order of the key, and the number of keys is order minus 1, that is x minus 1. Now coming to the minimum number of keys. So the root node can have minimum 1 key. The other nodes apart from root can have ceiling of m by 2 minus 1. Now what is this ceiling? So ceiling tells us the upper value. So consider if I am dividing 8 by 2, so it is giving me 4, but consider I am dividing 9 by 2, it is giving me 4.5. So it will take the upper value of 4.5, that is 5, and 5 minus 1, it will give me 4. So whenever we want to find the minimum number of keys for root node, it will always be 1. For other nodes, it would be ceiling of m by 2 minus 1. Now what are the minimum number of children? For the root node we can have at most 2 children. For the leaf node we won't be having any children because leaf node is the last node in the tree. And coming to the internal node, we will be having ceiling of m by 2. This is the minimum number of children internal node can have. Leaf node will be having 0 and root node will be having 2. The minimum number of keys in the root node would be 1, that is there would be only 1 minimum number of key. The other nodes can have ceiling of m by 2 minus 1. The maximum number of keys every node can have is x minus 1, where x is the order of the. So insertion in B tree always happens from the leaf node. So you have to make sure that whenever you are inserting any value in the B tree, it always happens from the leaf node. It doesn't happen from the root node. So we have to insert the value only from the leaf node. If it overflows the value, then we push it to the internal nodes or the root node, but the value insertion start from the leaf node itself. So let's take a node of a binary tree. Now in this particular node, we will be having a block pointer which contains the reference to the child node. Then we have a key, and then we have a data pointer which contains the reference for the record in the disk. So what we will do is, this is the node. Now in this particular node, how many block pointers can be there? So the block pointers is equal to the order of the tree. So at max, the order of the tree is considered 3. So there will be 3 block pointers. So here there will be a block pointer BP1, then there will be a key K1 D1, then there will be again a block pointer BP2, then there will be a key K2 D2, and then so on. There will be multiple block pointers as well as key and data pointers. Now consider that if someone provides you the block size, the block pointer size and data pointer size, how you can find the order of that particular tree. So this is the block size, like this particular block has a size, so that is called as a block size. Now this is the block pointer size, and this is the key as well as the data pointer size. You can derive the formula for the same. So here m is the order of the tree and the number of block pointers depends on the order of the tree. If the order of the tree is 3, then there will be 3 block pointers. If the order of the tree is 5, there will be 5 block pointers. So we will multiply m with pb, where m is the order of the tree and pb is the block pointer size. Now coming to the key as well as data pointer. Now key and data pointer are always 1 less than the order of the tree, because there are some block pointers and there are some keys and data pointers, and keys and data pointers are always 1 less than the block pointer. So it will be m minus 1, that is order minus 1, into K stands for key, and PD stands for the data pointer size. So we will add this key and data pointer size together, and then we will multiply it with m-1, that is order -1, and that should be less than the block size. So here the number of keys a node with m children can have maximum of m-1 keys. Number of block pointers, each node has m block pointers to the child node. Number of data pointers, each key has an associated data pointer, so there are m-1 data pointers. So the data pointers and keys are always m-1, that is 1 less than the block pointers, and the block pointers are always the maximum of the order of the tree, that is x or m, that is the order of the tree. Now let's say you have a block size B of 1024 bytes, you have a block pointer size PB as 8 bytes, you have a data pointer size PD as 12 bytes, and you have a key size K as 16 bytes. Find the order of the tree. So you have to find the order of the tree. So we'll come to that formula where we will multiply order of the tree with the block pointer size, that is PB, that is 8. Then we will subtract 1 from the order because the key pointers and data pointers are always 1 less than the block pointers. So that is m-1. Then we will add the key pointer as well as the data pointer, that is 16 plus 12, and that is always less than and equal to block size, that is 1024. So here we can find the order of the tree is 29. So in this way we can find the order of the tree when all these values are provided to us. So what are the steps to insert values into the binary tree? So first one is start at the root and recursively move down to the tree to find the appropriate leaf node where the new value should be inserted. So as I told that insertion in the binary tree always happens from the leaf node. So we have to find the leaf node where we can insert the value. Now second one is insert the value into the leaf node in a sorted order. So we have to insert the value into our leaf node in a sorted order. If the leaf node has fewer than the maximum allowed keys, that is order -1, this step is simple. So consider that if I have to insert 1, 2 and 3 and this is my leaf node. Now this particular leaf node doesn't have any data at all. So what I'll do is insert 1 and then I'll insert 2. But consider the order of this particular tree is 3. So the maximum number of keys which can be inserted is m-1, that is order -1. So 3 minus 1 is 2. So we can only insert 2 keys at max in the leaf node. But consider that if I have to insert 3 also, then how the insertion will happen? So if the leaf node contains the maximum number of keys after the insertion, it causes an overflow. So what we have to do is we have to split the nodes. So divide the nodes into 2 nodes. The middle key median is pushed up to the parent node. So what we'll do is we'll find the median of this, that would be n by 2. So we'll find n by 2 and we'll find that 2 is the median node. So it will be pushed to the parent node, and then once it's pushed to the parent node, it can hold 2 elements. To the left of this particular parent node, we will be having 1. To the right of this particular parent node, we will be having 3. So this will be a lesser value than 2 and this will be a greater value than the parent node. So the left half or the original node stay in the place while the right half forms a new node. So insert the median into the parent. If the parent node also overflows after this insertion, recursively split the parent node and propagate the median up the tree. So the fourth one is if the root node overflows. So consider the node in which I am inserting the data, and because of this I am pushing the data to my parent node. Like whenever I am inserting the data into my leaf node, if the leaf node is overflowing, I am inserting or pushing the data into my parent node. But consider that the parent node also overflows and the parent node is the root node. Then what we should do in that case? So which can happen if it already has the maximum number of keys, split it into 2 nodes and the median becomes the new root. So what you have to do is you have to split it again into the 2 nodes and then the median becomes the new root. So we can say that this increases the height of the B tree by 1. So this will increase the height of the B tree because earlier we had only 2 particular levels, but now we have 3 levels. So let's see that how we can create a B tree of a given order and how we can do the insertion of the values into our B tree. So create a B tree of order 3 and insert values from 1, 4, 6, 8, 10, 12, 14 and 16. So the maximum number of children a tree can have is equal to the number of block pointers, which is equal to the order of the tree, that is order of the tree is 3. Now coming to the maximum number of keys a given node can have, that is order -1, that is 3 minus 1, so 2. So the maximum number of keys a node can have here is 2 and the maximum number of children a node can have is 3. So insertion in B tree happens from the leaf node and the values are also inserted in sorted order. So the element in the left of the root would be having less than the root and the element in the right of the root would be having greater than root. So if this is the root and any element which is inserted in the left of the root would be having lesser value than the root, and the one which is inserted into the right of the root would be having a larger value than the root. So step 1. Start at the root and recursively move down to the tree to find the appropriate leaf node where the new value should be inserted. But this is a new tree which we are creating, so we will be starting from the leaf node. So we have to insert the value into the leaf node in sorted order. So the first value is 1, I've inserted 1. The second value is 4, I've inserted 4. So if the leaf node has fewer than the maximum allowed keys, that is order -1, the step is simple. So this step is simple. We have inserted 1, we have inserted 4. But here it is told that the maximum number of keys a node can have is only 2. Now we have to insert 6. So how can we insert 6? So what we will do is, in the step 2, if the leaf node contains maximum number of keys after the insertion, it causes an overflow. So split the nodes, divide the nodes into 2 nodes. The middle key, that is median, is pushed up to the parent node. The left half of the original node stays in the place while the right half forms a new node. So 1 and 4 is already inserted in my node. Now I have to insert 6. But here the maximum number of keys a node can have is 2. So I have to insert 6. So what I'll do is, I'll find the median including the 6. So that would be n by 2 because the number is odd. So the median would be 4. So what I'll do, I'll push 4 to the parent node, and then 4 will be created as a parent node, and in the left of 4 I'll be having 1, and in the right of 4 I'll be having 6. So this is how we split the node and we push the median of the node to the parent node. So here you can see that we have created a new node, that is a parent node. Now in this node, the left of 4 is having 1 and the right of 4 is having 6, because this value should always be less than the parent node and this value should be greater than the parent node. Whenever there is a overflowing which happens, push the median of the node to the parent node. Now we have inserted the median into the parent node. If the parent node also overflows after this insertion, recursively split the parent node and propagate the median up the tree. But here the parent node has not overflowed. So now we have to follow the step 2 again to insert other elements. So we have inserted 1, we have inserted 4, we have inserted 6. Now we have to insert 8. 8 is greater than 4, so it will come into the right of 4, so we'll insert it here. After 6, 8 is inserted. Now we have to insert 10. Now again the same situation is coming where we are overflowing the data. So because of which what we'll do is, so we'll push the median to the parent node and we'll create a new node in the right to insert 10, as 10 is greater than 8. So here we have pushed it to the parent node and here we have inserted 10. So to the left of 4 we are having 1, to the right of 4 we are having 6, to the right of 8 we are having 10. Now we have to insert 12. So we can insert 12 to the right of the 8 because it is greater than 8, so we have inserted 12 as well. Now we have to insert 14, but how we will insert 14? Here the data is already overflowing, so we'll send the median to the parent node. But now parent node is also overflowing, so we have to push the median element of the parent node to the root node. So what we will do is, we have pushed 8 here. Now to the left of 8 we are having 4. Now 4 is having 1 and 6. To the right of 8 we are having 12. Now we are having 10 as the left of 12 and 14 as the right of 12. So let's understand from here what we have done is, here we have pushed 12 to one step above. So here 12 is here and 4 is here. Now here, since there were 3 elements again which was overflowing, so we have pushed the median 8 to one more above node, that is a parent node. So here we have pushed 8 here. Now to the left of 8 we are having 4, to the right of 8 we are having 12, to the left of 4 we are having 1, to the right of 4 we are having 6, to the left of 12 we are having 10, and to the right of 12 we are having 14. So in step 3, if root node overflows, which can happen if it already has a maximum number of keys, split it into 2 nodes and the median becomes the new root. This increases the height of the binary tree by 1. So here we can see that the height of binary tree was having only 2 levels, 0 and 1, but here the height of tree has been increased. So this is how you can do an insertion in our binary trees. Let's learn about the deletion in the binary key. So in the insertion, we were saying the maximum number of keys a given node can hold. But in the deletion, we need to see the minimum number of keys a given node should have. Because consider if I delete all the values which is present in our node, so it will be violating the binary key rules. So we have to search for the minimum number of keys which a node can have. So here we are considering a binary tree of order 4. So the minimum number of keys is ceil of m by 2 minus 1, that is 4 by 2 minus 1, that is 2 minus 1, that is 1 key. So when the order is 4, the minimum number of keys a node can have is 1 key. So let's start. So the step 1 is, begin at the root and recursively move down the tree to find the node that contains the key to be deleted. So we'll start from root and then we will search for the key which needs to be deleted. Now the step 2 is, consider the case where the key is a leaf node. So we have to consider a case where we have to delete a key which is present in a leaf node. So first one is, simply remove the key from from the leaf node. So what we have to do is, first we have to search for the key which we need to delete, that is 10. So we'll come here and we'll see the root is 40 and 50. So the key that is 10 will be less than 40. So we'll come in the left, and here we have found the 10. Now here what we have to do is we have to delete 10, but we have to make sure that the minimum number of keys remains 1. So is the minimum number of key remaining 1 after deleting 10? Yes. So we can simply delete 10. So if the node still has the minimum required number of keys, the deletion is complete. So the deletion is complete because it still has the minimum number of keys which is required. Now coming to the case 2 where the key is in the leaf node, but there could be a possibility that if I am deleting that particular key, the node is having less than the minimum number of required keys. So consider here I am deleting 20. So if the deletion causes the node to have fewer than the minimum number of keys, proceed to the borrowing or the merging step. So we have to follow a borrowing or the merging step. Now how we can follow that? So here I have to delete 20, right? But if I delete 20, the minimum number of key which is needed is 1. That would be violated. So what I'll do is, if the node has a sibling with more than minimum number of keys, you can borrow a key from the sibling. The parent key between the node and the sibling moves down through the node. Here I have to delete 20. What I'll do is I'll find the sibling, immediate sibling of 20. So there are no siblings in the left, there are some siblings in the right. Now I'll see that if the number of siblings is having more than the minimum number of keys, so the minimum number of key is 1 and the sibling is having 2 keys. So we can borrow 1 key from this particular sibling. This node A can borrow a key from node B so it can maintain the minimum number of keys. So this particular borrowing happens via the parent node. So what happens here, we are deleting something which is in the left of the parent node. So we'll be picking the smallest value from the parent node. So here it is 40 and 50. So we'll be picking 40. We will be giving 40 here. And then we will be deleting 20, and from here, since parent needs to maintain the 2 keys because it has borrowed from the sibling, not from the parent. So from the parent we will pick up the maximum value and we will go ahead and provide it here. So now it will be 4750. Here is 40 because we have deleted 20, and here it is 44. So the minimum number of keys is maintained here as well and here as well. So there is a borrow which has happened between these 2 siblings via the parent, right? Now here you would be thinking that why we are sending the smallest value here and why we are borrowing the largest value here. So here we are deleting from the left node of the parent. So left node always contains the smallest value. So from here also we will be using the smallest value so that this particular root and parent node does not have any unbalanced or unsorted way in which the data is stored. So we will give 40 here, and here we will pick the largest value because here we are replacing the key from the right of this particular 40, right? So from the right of this particular 40, if we are replacing the value, we need to pick up the highest value. So we'll pick 47 and we'll put it here. Now consider another case that the key is again a leaf node, but when we are deleting a given value or a given key, it can't even borrow from the sibling because sibling also has the minimum number of key. So consider that I have to delete 40. And I can't borrow from my sibling because sibling also has the minimum number of key which is required. If I borrow from the sibling, it will be short of the key, right? So in that case, merging happens. So if borrowing is not possible, that is the sibling also has the minimum number of keys, merging the node with a sibling happens. Now the key from the parent that separates the 2 nodes move down into a newly merged node. If this causes the parent to have too few keys, repeat the borrowing or merging process at the parent level. So what we will do here is we will merge this 40 and 44, and from the parent node, which is a common between these 2 keys, that is 40 and 44, that is 47, will come down and perform in this particular merging. So it will be 40, 47 and 44, and then we can go ahead and delete 40. So what happens is merge the node with the sibling. The key from the parent that separates the 2 nodes move down in a newly merged node. So it will be 50, 44, 47 since we need to store our data in a sorted manner, and here it will be 52 and 59. So this is how the merging happens when the sibling doesn't have more than the minimum number of keys, and this is how borrowing happens when the sibling has more than the minimum number of keys. Now coming to the next case, when the key is an internal load. In the last case we saw about the leaf node. In this case we'll be seeing about the internal load. So here we have to delete 20. Now 20 is an internal node here. So how the deletion happens? So what we do is we replace the key with its predecessor, the largest key in the left subtree, or its successor, the smallest key in the right subtree. So here we have to delete 20, but the minimum number of keys which is required for a given node is 1. So if we delete 20, it will violate the binary tree rule. So how we can delete 20 when 20 is an internal node? So what we will do is we'll replace the key with its predecessor or successor. So we will replace it with its predecessor or successor. What is predecessor? The largest key in the left subtree. So we'll go into the left subtree and we'll find the largest key, that is 10 and 11. So we'll replace 20 with 11 and we will delete 20. Here we can replace it with 11 because the minimum number of keys which is required is 1. So here if there is 10, the minimum number criteria is matching. So delete the predecessor or successor key from the corresponding subtree. So we can delete this particular key which is a predecessor or successor to this particular 11. Now if this causes an underflow, the node has few keys, proceed to the borrowing and merging step. So if this particular causes an underflow, we have to go to that borrowing and merging step. Now consider if we have to delete 11 and 11 is the minimum number of keys a node can have is only 1, and if we delete 11 it will violate that property. So we have to do that borrowing and merging step which we discussed in the leaf node. In the same way it will happen here as well. Now let's learn about B plus tree. So a B plus tree is an extension of B tree and is commonly used in databases and file system to maintain sorted data and allow for efficient insertion, deletion and search operations. B plus tree is also a balanced tree, meaning all the leaf nodes are at the same level. So in B plus tree also all the leaf nodes are at the same level. It is a balanced tree. Basically it is an extension to the B tree. Now here I am saying that B plus tree is an extension to the B tree. Then what are the common differences between B tree and B plus tree? So the key difference between B plus tree and B tree lies in how they store the data and how the leaf nodes are structured. So there are some differences in how they store the data and how the leaf node of them are structured. So the very first one is, in B tree all the actual data or references to the data are stored in the leaf nodes and internal node only stores the key. So in B plus tree what was happening was every node was storing key, data pointer and block pointer. The block pointer points to the children, the key points to the value, and the data pointer points to the address where the record is present in our hard disk. Now in this particular B plus tree what happens is, in leaf node only we store the key and the data pointer. In other internal nodes we only store the key, not the data pointer. So only in the leaf node we store the key and the data pointer, and there is only one block pointer which is present per node which points to the next leaf node which is present in this B plus tree. So in B tree what used to happen was, there was a key, there was a data pointer, there was a block pointer, and this particular block pointer used to point to null when it was a leaf node. But in B plus tree there is key and data pointer, and then there is only one block pointer per node which points to the next node which is present in this leaf. Now coming to the next point, in a B plus tree leaf nodes are linked together in a linked list fashion. So they are linked together in a linked list fashion and they use the block pointer for the linking purpose. Now each leaf node can have only one block pointer which contains the address to the next leaf node. So this is how the leaf node looks. It has key, it has data pointer and it has block pointer which addresses to the next leaf node which is present in the system, and it follows a linked list fashion. During inserting the value in B plus tree, a copy of the key is always stored in the leaf node. As I told that the internal nodes only have the key, it doesn't have the data pointers where that particular record is present in our disk. All the details are present in the leaf node only. So what will happen that whenever we insert any value in the B tree, the leaf node always have a copy of that particular node in the leaf node in a sorted manner. So here if I am inserting 30 and 70 in the leaf node, I'll be having a copy of 30 and 70. Because in the leaf node we have the data pointers, in the internal nodes we don't have any data pointers, we only have key. Now coming to the internal node. So internal node do not store data pointer, only keys and the child pointers. So in the B tree what used to happen was, there was a key, there was a data pointer, and then there was a block. But here what happens is, in the internal node there is only key, there is no data pointer which is present, and there are some block pointers which points to the child nodes. So this is how the internal node is designed in B plus tree. So this allows more keys to be stored in each internal node, leading to a lower height and more efficient operation. Now data pointer don't needs to be stored, so the amount of size which data pointer was consuming is reduced. So we can go ahead and insert more number of keys in B plus tree rather than B trees, and this will help us to have a less height of the tree rather than B trees. Now what is the structure of B plus tree? So the first is root node. The top node of the B plus tree which points to the first level of internal nodes or directly to the leaf nodes if the tree has only one level. So this is the root node which points to the internal nodes, and if there are only two levels of nodes which are present, then it points to the leaf nodes. Now coming to the internal nodes, these nodes contain only keys and pointers to the child node. This node only contains key and the block pointers, or you can say the pointers to the child node. It doesn't contains any data pointers, it only contains the key. So it will be K1, K2, K3, K4, and in between there will be some block pointers for this particular children's. Now coming to the leaf nodes, so these node contains keys as well as data pointers. So the leaf node contains keys as well as data pointers, and there is only one block pointer which is present, which points to the next leaf node, enabling quick traversal of records. So all the records is present in the leaf node only. If we want to search for any record, we have to just go to the leaf node and traverse the leaf node and find that particular record. What are the advantages of B plus trees? So B plus trees have a balanced structure, meaning all the leaf nodes are at the same level. So all the leaf nodes would be at the same level. This balance ensures that the search operations require logarithmic time relative to the number of keys, making it very efficient even for the large data sets. So even there are large data sets, we store all the data in the leaf nodes, so the traversal is very easy and we can find any data, insertion, deletion, and like reading of the data is performed in the logarithmic time. Now coming to the second point, the structure of B plus trees allows for direct access to the data. Since the internal nodes contain only the keys, searching for a specific value can be done quickly by navigating through the tree down to the leaf node where the data is stored. So in the leaf node, since the data is stored and the internal nodes only have the keys, the leaf node have the key as well as data pointer, and it also has a block pointer which points to the next leaf node. So it helps us to get the data very fast, and the traversal is also very easy. Now B and B plus trees both are used to implement indexes in databases. So B tree and B plus tree both are balanced trees, but there are some differences in the structure of B and B plus trees. So in B tree, all the nodes have the same structure. There is a block pointer which consists the address of the child node, then there is a key, then there is a data pointer which points to the location where data is stored in the hard disk or secondary memory, you can say, and again there are some block pointers. Now coming to B plus tree, so there is some structural differences between the internal and the leaf node. Now in the internal node, there is a block pointer which points to the child address. Then there is a key only which is present. There is no data pointer which is present in the internal node. But when it comes to leaf node, it has a key, it has a data pointer, and again it has a block pointer which points to the next element or next node which is present in the leaf. So basically there is a linked list structure which is formed in the leaf, and in the leaf node only you can find out the data. So let's understand from an example. Think of a B tree as a directory structure on your computer where folders contain both name and pointers to subfolder or files. So consider that there is a directory which is present in your computer. Now there is a folder. So there would be some name for this particular folder. So this is the key of this particular folder. Now in this particular folder, there would be one more folder, or you can say child folder. So we can say that this is the child folder. Now this particular folder is considered to be a node. Now this particular node is containing the key as well as the block pointer, or you can say the pointer to the child which is present here. So this contains the node as well as keys and pointers to the subfolders or the child folders. Now coming to B plus tree. So imagine a library catalog where all book records are listed in a sorted linked list manner, which is leaf nodes, and the internal nodes only contain pointers to guide you to the right part of the catalog. So consider I want some books in the comedy section. So I'll go to this comedy section. Now in this particular comedy section, I can get some books which are sorted in the linked list manner. So this particular comedy section is helping me to find out where all the books would be present, and here I can find the books which would be present in the linked list manner. So I can say that this is the leaf node and this one is acting as an internal node because it is telling me that where exactly these particular things are present. Now coming to the basic differences. So the first one is data storage. So keys and associated pointers to the data are stored in all the nodes. So in B tree, keys and associated pointers are stored in all the nodes, internal as well as leaf node. But coming to B plus trees, all the actual data is stored only in the leaf node. So the data pointer is only stored in the leaf node, and internal nodes only contains keys and pointers to the child node. So internal node, we have only keys as well as pointers to the child node. So this is the block point that points to the child node. So we can say that in B tree, all the nodes has the data pointers which is present, but in B plus tree, the data pointers are only present in the leaf node. Now coming to the next point, that is leaf node linking. So there is no inherent link structure which is present between the leaf node. So there is no linked structure which is present between the leaf nodes in the B trees. But coming to B plus trees, leaf node are linked together in a linked list manner. This linked list structure allows for efficient sequential access, making range queries faster and easier. Since all the data is present in the leaf node, we can start our searching from the leaf node, and all the leaf nodes are interconnected with each other, which has key and data pointer. So it would be very easy to search for the data which is present in the leaf node. So searching would be very fast. Now coming to the search performance. So access time can be slower for certain type of queries because you may need to traverse multiple level of trees to find the data. So in B tree, what happens, consider if this is a B tree which is having some internal and some child nodes. Here consider if I want to search for a data, there might be a possibility that I need to traverse the entire data set which is present in this particular tree. But in B plus tree, what happens that since all the data is stored in the leaf node only, we need to only traverse this particular leaf node or the linked list structure which is formed at that particular leaf node. So leaf nodes are linked together in B plus tree, allowing for efficient sequential access and range queries. So it is very helpful for range queries because we need to only traverse the linked list which is present at the end of the tree. Now coming to the space utilization. So since data is stored throughout the tree, B trees might have lower space utilization in the nodes. So since data is stored everywhere, there would be very less space utilization because in a node you need to reserve a space for a key pointer, then the data pointer, and then the block pointer. The storage of key and data pointers in a given node would be very less. Now coming to B plus tree. So B plus tree typically have better space utilization because internal nodes are only used for keys, allowing more keys to be stored per node. So here you have to store key, data pointer, block pointer, but in B plus tree what happens, you have to only store a key and then there are block pointer. So since the data pointer is not stored here, the size of the data pointer which is getting occupied here in the node, which won't be needed here. So here we can store more number of keys because there are no data pointers, but here since we have a data pointer associated to a key, there is very less space and very less keys which can be stored in a given node. So these are some of the basic differences between B and B plus tree. Oftenly B plus tree is mostly used in some of the cases because the search performance is very good. We can use it for the range queries. Again, the way in which the data is stored is also very optimal because you only need to go to the last or the leaf node and search for your particular data rather than traversing the entire. So the very first question which would be coming to your mind is, why do we even need to scale our databases? What is the use case behind it? So let's just understand a normal architecture or a process of users sending a request to access the data present on the internet. So right now we are having a device that could either be your PCs, mobile, or any computers. Now from this particular device, you go to the browser. You make a request, consider www.facebook.com, google.com or anything. So here we have taken www.example.com. Now whenever you provide this particular URL, just to get the data from the server, what we do is we need to provide the IP address. So we need to fetch the IP address of this particular URL. So how we can fetch the IP address? So if this particular URL has been hit by the browser like in the previous times, or if the data is saved in the cache, first we do a lookup on the cache, and if it is present, we provide that particular IP address. If it's not present, then we do a DNS lookup. So it will check in the cache of the browser as well as operating system if the IP address corresponding to this URL is present or not. If it's present, it will return the IP address here, and then device will take the IP address and do a connection with the server and fetch all the details. But if the IP address is not present, it will do a DNS lookup, that is a domain name server lookup. So it will pick the domain name and then it will provide the particular IP address. So here we have got the IP address. Now using this IP address, we make a request to the server because whenever we are accessing any website, all the details like databases, backend functionality, static content, dynamic content relies in the server itself. So we need to make a connection to the server and then send a request to the server. So first we will try to establish a connection with the server using the TCP and IP protocols. Once we have established a connection with the server, we will pick the IP address and we will send a request to the server. Now server is having databases, static content, dynamic content, which is basically the backend functionalities. So server will process the request and then gives away the response in the form of HTTP status code along with the content. Now that particular content would be rendered and then it will be shown in our device. Now this is how the normal architecture of a user sending a request and then fetching the details works. So as the data increases or the number of user increases, the server also needs to increase its storage space. So because of that reason, what we do is the database which was present earlier in the server is now decoupled and made as a all-alone entity. So now we have a database as a all alone entity. So now if the storage increases, that could be accommodated in the databases. So the request which is made by the user from the device will go to the server. Server will make the same request to the database, as all the data which was present inside the server is now present in the database. So all the request has went to this particular database, and now this particular database will give me the result and server will give me the response. Again, if you see this particular architecture, consider if there is any crash which has happened at the server, we won't be able to get the results, right? Because there could be multiple users who are making the request and server can't handle that much load. So there could be a crash in the server. There could be also a crash in the database. Then again, we won't be able to fetch our details. So this particular system is not scalable, because if there are more number of users who are coming and making requests, we need to accommodate that request, right? We can't say that the server has crashed or the database has crashed. That is a bad user experience. So this system is not scalable. As the number of user grows, it will require the scalability in our systems. So that is why scalability is needed. So how we can scale our databases? So there are two types of scaling. First one is a vertical scaling, and second one is a horizontal scaling. Now what happens in vertical scaling? So in vertical scaling, if there are one server, right now server S1 is present. So what it will do is it will increase the number of CPUs as well as RAM of this particular server, so that it can accommodate more number of requests. So this is what happens in the vertical scaling. But there is an extent to which we can increase the number of CPUs or number of RAMs in our system. That is why vertical scaling is mostly used in small businesses or where the traffic is not very much. Coming to horizontal scaling, so if there was one server earlier, in horizontal scaling we make more number of servers. So there are more number of servers or instances which are made. So consider if one server fails, what will happen? The other server will accommodate the request. So in horizontal scaling, we increase the number of servers or number of instances. In vertical scaling, we increase the CPUs, cores or RAMs so that it can accommodate more number of requests, but only to a certain extent. So now coming back to the last example which we discussed. So there was a device. Now in the device, we open the browser, we provide the URL which we want to fetch or the website which we want to fetch. Then for that particular URL, we need the IP address so that we can go ahead and ask the server for the details. For the IP address, first we need to check in the cache of our browser or operating system if the IP address is present. If it is present, we will return the IP address, and then that particular IP address will be used to establish a connection with the server and get the details. If the IP address is not present in the cache, we used to do a DNS lookup, that is domain name server lookup. From here we get the IP address. Now the device using the IP address first will try to establish a connection with the server using TCP and IP protocols, then we'll send away the request to the server. Now in the last example, what was happening was, if there is only one server which was present, and if there are more number of requests which is coming to that particular server, there could be a possibility that server won't be able to accommodate that particular load or that particular users. So because of which there could be a server crash or failure. So just to accommodate that, we are doing a scaling of the server. So now scaling, we are doing the horizontal scaling. So here we have horizontally scaled the server. Now there are three servers, S1, S2 and S3, in which what we have done is we have increased the server using the horizontal scaling. So now the server have been increased. So we can say now the crashing is accommodated here, because even if one server crashes, we have multiple other servers to accommodate the request. But now user is sending the request, there could be multiple requests R1, R2, R3 by different user. So how the server will know, or how the user will know that which particular server will be accommodating the request? So for this we have a load balancer coming into picture. Now what the load balancer does is, if there is any load which is coming to the server, it will go ahead and see in which particular server the load is the least, or which particular server has the less number of requests. It will just go ahead and accommodate that particular request to that particular server which is having the lesser load. So it just balances the load between the servers. Like if there are huge load which is coming to our website, it will just go ahead and balance that particular load in different server so that the server crashing doesn't happen. So we have used the load balancer here, which can balance the request which is sent to our server. So send request to the server having lesser load. So that is what load balancer does. Now we have sent the request to the server and load balancer is taking care of all the requests. But here earlier we had only one database. Now consider there could be a possibility that that particular database also crashes. So for that reason also we need to do a database scaling. So for that particular database scaling, again we'll be using a horizontal scaling. So we will be scaling our databases so that it can accommodate more number of requests, and even if one database crashes or fails, there would be more number of database to accommodate the request. Now the scaling in databases happen in a different way. What way it happens? So basically it happens in a data replication way, where in the database we have a master database and then a slave database. So this is a master database, or this you can call it as a slave, or you can say agent database. Now the master database handle all the write operation which is coming, like if someone is creating an account, signing in, signing up, so all the write requests are coming to this particular master database. And in the agent or the slave database, we accommodate all the read operations. So we have two databases mostly, one is master database, one is agent or the slave database. In agent database, we accommodate all the read request. In master database, we accommodate all the write request. Now there is only one master database which is present in the scalable system, but there could be multiple slave databases or the agent databases. So here we have one master database and then there are two slave database. Now what happens if this particular master database crashes? So there are certain algorithms which make one of the slave database as the master database whenever there is a crash in the master database. Now here we have a master database and slave databases. Master accommodates all the write request and slave accommodates all the read request. Now how we will know that which particular request which is coming to our system will be going to which particular slave database? Because there are two slave databases. So if there is any read request coming, how we will know that which particular request will be going to which particular database? So again here also we introduce the concept of load balancer, which tells that this particular request will be going to this particular slave database. Now this is how we are scaling our system. All the crashes or the server failures or the database failures which can happen is accommodated now. But you know that if we are just querying into our database, it takes a lot of time and it is very expensive. Like a request is coming, then it is going to the server is making a query to the database. So that takes a lot of response time and that is very expensive operation, because of which we introduce caching. So what caching does is caching reduces the response time, because here we store the values in the format of key and value pair. What will happen that whenever a device is making a request to the server will first go ahead and search in the cache if the data is present, because for some of the frequently used queries we can just go ahead and cache that particular data, because every time that query is made, that particular data needs to be sent. So it will go ahead and search if in the cache the data is present or not. If it is present, it will here only return the response and that will be rendered and shown in the device. If it's not present, then only it will go to the database and make a query, and that particular data will be gone to the cache and then we can see in the response. So in this way we scale our system so that there are no crash, no failures. It can accommodate more number of user requests and we can get our desired results in desired duration of time. So this is how we can scale our system from 0 to, you can say, lakh or million of users. Now in the user journey, what happened? First was user action sending a request. Second was the browser parses the URL. Third was a DNS lookup to get the IP address. Fourth was establishing a connection with the server. Fifth was sending the HTTP request to the server. Sixth was server is processing the request. Seventh was browser receives the response. Eighth was displaying the web page. And ninth was caching the data. So in this way the user journey happens. Now the user sends a request by entering the URL or clicking a link. The browser then translates the domain name into IP address through DNS lookup, establishes a connection with the server, sends an HTTP request and receives the response. So this is how the user journey was happening. Now the browser then processes this response, renders the web page and display it to the user. So we get the static and dynamic content from the server. Now it gets to be rendered and then it is displayed to the user. The process involves multiple layers of networking, data transfer and client and server interaction, all working together to deliver the desired content to the user screen. So everything works together and we get the desired result on our screen. Now scaling in database is a crucial topic in development, mostly when the application grows and the volume of data increases. So whenever the application grows, the volume of data increases or the number of user increases, it's best to scale our system. Now there are some scaling techniques which are present. First one is vertical scaling, that is scaling up. Second one is horizontal scaling, that is scaling out. Third is database partitioning. Fourth is replication. Fifth is sharding. Sixth is caching. And seventh is load balancing. So let's learn about each and every one of them in depth. So the first one is vertical scaling. As discussed in the last slides, that what we do in the vertical scaling is we increase the CPU as well as the RAM of our server so that it can accommodate more number of requests. But there is an extent to which only we can increase our CPUs as well as RAM. So if there is a server, we increase the capacity of instances of RAM and CPU so that it can accommodate more number of requests, but only till a certain extent. So vertical scaling involves increasing the capacity of single database server. Now in vertical scaling, how we can vertically scale our system? system. So first one is adding more resources. So upgrading the server by adding more RAM, faster processors, or larger or quicker storage. So whenever we add more RAM, faster processor, or larger or quicker storage, we can scale our system. This helps the server to handle more number of requests and store more data. Now coming to the next pointer, that is improving performance. So tweaking the database settings, optimizing queries, and indexing the tables to make the better use of hardware. So we can tweak the database settings, optimize our queries, and index our tables to make the better use of our hardware. Now coming to the third point, that is upgrading to a stronger machine. So moving the database to a more powerful server, like switching from a regular server to a high performance cloud instance. So whenever we switch to a high performance cloud instance, we can do the vertical scaling and we can get our data very fastly and very quickly. Now, why vertical scaling is also called as scaling up? Because here we increase the more number of CPUs as well as RAM. So we scale up our system or the same server only in which we are increasing the number of CPUs as well as RAM. Now, what are the advantages of vertical scaling? So it is easy to set up because it usually doesn't need changes to the app or the database structure. So we don't need to do any changes to the app or the database structure. We only need to increase the CPUs as well as RAM. So it is easy to set up. Now coming to the next point, it is simple to manage since everything is kept on one server. So since everything is present only on the one server, we can easily manage each and everything. We don't need to go to different servers to manage different things. Now coming to disadvantages, first one is limited by the hardware's maximum capacity. As I told that there is only one certain extent to which you can increase the CPUs as well as RAM. So there is a limitation. Now coming to the second point, so it is expensive as high-end hardware can be costly. So a high-end hardware can be very costly, because of which it is also very expensive. Now coming to the third point, that is single point of failure. So since there is only one server in which we are increasing the CPUs as well as RAM, what if the server fails? All the system will be go down, right? So if the server fails, the entire database goes offline. So if the server fails, the entire database goes offline and we won't be able to process the request of different users, and it will be resulting into multiple 500s or server not found. Now coming to the next one, that is horizontal scaling, which is also called as scaling out, because here we are not scaling the resources of the server, rather we are scaling the server. So if there is one server earlier, we are adding more instances or more servers after scaling. So if this is server 1, server 2, server 3 and server 4. So horizontal scaling involves spreading the database workload across multiple servers. So whenever we spread the database load across multiple servers, we call this as horizontal scaling in terms of databases. Now this can be done in different ways. First one is database replication. Replication is the process of copying the data from one main server, master, to one or more backup servers, that is slave. So I told earlier that in the database replication, we deal with the master slave, or you can say master agent architecture, where mostly master handles all the write operations and the slaves or the agent handles all the read operations. So here master slave replication, the master server manages all the write operations, while the read operations are distributed among the slave servers, or you can say agent servers. So this setup improves the read performance and provides redundancy. So it helps us in improving the read performance of our system, because there are multiple slave databases which is present, or agent databases which is present, which can handle multiple requests which is coming to our server, that is read request. Now coming to the next one, that is multi-master replication, which is also a part of database replication. In this, multiple server handle both read as well as write operation, increasing availability and the write capacity. So here multiple server handles both read as well as write operation, so that it can increase the availability as well as the write capacity. So however, it also introduces challenges in managing conflicts. So since if the multiple server are handling read as well as write operation, there could be some conflicts such as dirty read, where read and write read, write conflicts are occurring. So because of this multi-master replication, there could be some conflicts which can arise. In master slave replication, basically there is a master which handles all the write operation and there is a slave which handle all the read operations in our database. Now coming to database sharding. Now what we do in database sharding, so consider if there is one database which is present here, which is having a table T. Now this particular table T is divided into different shards. So it divides the data between multiple tables in different database instances. So now T is broken down into T1, T2, and T3, and all these table relies in different database shard, that is D1, D2 and D3. So it divides the data between multiple tables in different database instances. So sharding involves partitioning the database into smaller, more manageable pieces shard, with each shard stored on a separate server. So the database is divided into different shards D1, D2 and D3, which is having different tables T1, T2 and T3, which is having all the data which is present in the table T. So there are two ways in which we can do the sharding. First one is range based sharding, in which the data is divided based on the range of a particular key such as data or user ID. So if there is a key which is present, on that particular key we will decide the range on which the data should be divided into different table. Like 1 to 5 is going to this table, then 5 to 10 is going to T2, then 10 to 15 is going to T3. So on the basis of range we divide the data among different tables. Now coming to the hash based sharding. So hash function is applied to the key, example user ID, to determine which shard the data should go to. So we apply the hash function on the basis of user ID or user key, so that we can decide that in which particular shard which particular data should go into. Now coming to the next way, that is caching. Now what happens in caching is we store the data of the most frequently asked queries. So it implements the caching layer to store frequently accessed data in the memory, reducing the load on the database. So we reduce the load on the database because consider if someone is accessing netflix.com and if someone is going to the movies tab. So this is something which is happening like each and every time when someone is logging in. So what we do is, for that particular operation we store that particular data into our cache, so that there is no DB operation which is happening, because DB operation can take a lot of response time and is also very expensive, while if we use caching we can get it in very lesser response time. Now coming to the next one, that is load balancing. So distribute the database queries across multiple servers using load balancer to prevent any single server from becoming a bottleneck. So what the load balancer does is, if there are multiple requests which are coming into our system, R1, R2, R3, load balancer decides that which particular request will go to which particular server, so that there is no one particular server which is being a bottleneck for anything. So it decides that which particular request will be going to which particular server. Now coming to the next way, that is partitioning. So it divides the large table into smaller partition that can be queried independently, improving the query performance. So what happens that if there is a database server, in that particular database server if we have a table T, it will divide this particular table into different partition, that is T1, T2, T3 in the same database server, so that that particular smaller partition can be queried independently. So it divides the data which is present in this particular T table into multiple table in the same DB instance. So it divides the data which is present in this particular T table into multiple table into the same DB instance, so that we have smaller partitions of table and the queries can result in a faster duration of time. So this is how we can scale our databases. Now, role-based access control is a security system that controls that who can access a database or system based on their role in the organization. So, based on the specific role in a given organization, we provide some access control to the users. Now, consider that there is a team which is working on making ID cards for the employees. Now for that they will need the details of the employees like first name, last name and different things. So we provide an access to the database to this particular team. Now consider that this particular team is doing some read operations on the database. That is okay because they need some user details. But consider if this particular team is doing some write access or doing some modification in the database. That is not allowed because this is a security breach. So for that particular reason only we provide some access. So instead of giving permissions directly to each user, the system creates role with the specific permission and users are assigned according to these roles. Now for example, a database administrator might create roles like DB read for reading the data and DB write for modifying the data. Only people with the right role can read and change the information. So we'll provide a DB read to this particular team so that it can read the details which is present in our database, but we won't be providing access for the DB write. Now what is role? So it is basically a set of permission which is associated with a job function. Example, there could be admin, there could be a manager, there could be a developer in different organization. So according to their job function, we provide a different role to different users. Now coming to the permissions, so these are the rights that are granted to perform certain actions such as read operation, write operation, delete operation. So whenever we provide some rights to certain users to perform some certain actions like read operation, write operation, delete operation, we give them permissions. Now coming to users, so these are the individuals who are assigned one or more roles. Now coming to the advantages, so it makes it easier to manage permissions, especially in big systems. So whenever we want to manage permissions, especially in bigger systems or bigger MNCs, we can use RBAC. Now coming to the next pointer, it lowers the risk of misuse by making sure users only have access to what they need for their role. So if there are two users, user 1 and user 2, if I've given the access for DB read, user 1 can only perform read operations. If I've given the user 2 as DB read as well as DB write, it can go ahead and do some modification as well as read the data. So according to the role, they are able to use the data. They can't go ahead and misuse any data. Now coming to the third pointer, that is it improves the security and help keep rules consistent across the system. So it helps us to increase the system security. Now, encryption in databases refers to the process of converting the data into a secure format that can only be read or accessed by someone with the correct decryption key. So what we do is, if there is a data D1 which is present in our system, we will encrypt this particular data into a secure format, like there would be some stars, there would be some A, B, C, there would be some equal to, like some special characters, some alphabet, mixture of everything. So we'll encrypt this particular data, and then the person who is having the correct decryption key can only go ahead and decrypt this data and read this particular D1. So this is what encryption in database means. So this helps in protecting sensitive information from the unauthorized access. Since we have encrypted our data, any person who is having the decryption key can only go ahead and read the actual data. Otherwise, the person will be seeing this special characters and alphabet combination, which doesn't make any sense. So we are securing our data from any unauthorized access or any hackers. So for example, an MNC might use encryption to protect their records in their database. Even if a hacker gains access to the database, they wouldn't be able to read the data without the decryption key. So even if the hacker have the access, it will be only able to read this particular data, not this data, because this data needs the decryption key, and which should be a correct decryption key. Now what are the types of encryption? First one is at rest, second one is in transit, third one is column level, and fourth one is full disk. So let's learn about each and every one of them. So first one is at rest encryption. So at rest encryption protects the data stored in the database by encrypting it whenever it's saved to the disk. So whenever we are saving our database to the given disk, or you can say secondary memory, it encrypts the data whenever we are saving the database. At that particular time only, it encrypts the data. This means that if someone gains access to the physical storage or the database files, they won't be able to read the data without the encryption key. So since while saving the data which is present in our database in the disk, we are encrypting the data, anyone who gains the access to our disk or our physical storage won't be able to read the data, because the data which is stored in the disk is in encrypted format. So example, a company encrypts employee salary records stored in their database. If someone accesses the database files directly, they see encrypted data like xyz123 @ instead of the actual salary figures. So whenever we are storing the salary data in our disk, we will encrypt that particular data. So whenever someone tries to access this particular data, they will be seeing this particular data, not the real data, because that requires a decryption key. Now coming to the next one, that is in-transit encryption. So in-transit encryption secures data as it moves between the database and the applications or the user. So whenever there is a fetching of data from the database which is happening by a user, it tries to encrypt the data that time only. So this is typically done using secure communication protocols like SSL, TLS to prevent the eavesdropping or the tampering during the data transmission. So for example, when you send an email, in-transit encryption ensures that the email content is scrambled while traveling to the recipient server. So whenever a user 1 is going to send an email to user, so this particular data is encrypted while traveling from user 1 to user 2 or sender to recipient. So even if it is intercepted, it appears as a random characters like this, and that is unreadable. Coming to the next one, that is column level encryption. So column level encryption encrypts specific columns within the database. This is used when only certain pieces of data like credit card numbers or social security numbers needs to be protected, leaving the rest of the data unencrypted for easier access. So whenever you want to encrypt some highly valuable data which is present in our database, you use this column level encryption, because column level encryption only does encryption on some specific columns which is having some highly valuable data. So for example, a database holds user information with a column for social security numbers, that is SSN. This column is encrypted, so an SSN like 1, 2, 3, 4, 5, 6, 7, 8, 9 might be stored at this particular way in the database, so that if anyone accesses this particular column, they will be able to see these special characters and need a decryption key so that this particular data will be encrypted. This is used whenever you want to encrypt some special column which is having highly valuable or highly risky data. Coming to the last one, that is full disk encryption. So full disk encryption encrypts the entire disk where the database is stored. This ensures that all the data that is stored on the disk is protected, not just the database but any files, logs or backups stored on that particular disk. So what we do here is we encrypt the entire disk which is having the database, some transaction logs, some backup files, so that if anyone has any access to the disk, he or she won't be able to see anything like the database, the transaction logs or any files which is present in the disk. So for example, a laptop which is used by an employee is encrypted. If the laptop is stolen, the entire disk is protected. So whenever our laptop gets stolen, we can be assured that our entire disk is encrypted, so no one can go ahead and access the data. So and the thief would be only able to see encrypted data like this one instead of the readable files. So if the thief who has stolen our laptop would be able to only see the data like this, which is in an encrypted format, and the thief won't be having the decryption key that will be only available with the user. So he or she won't be able to fetch anything from our laptop. So what are some of the common data masking technique and what exactly data masking is? So data masking means hiding or changing sensitive information so it's protected from unauthorized access. This allows the data to be used for things like testing, analytics, or training without exposing the real data. The goal is to create a data that looks real but isn't actually the original information. Now for example, a bank needs to train its machine learning model to detect the fraudulent transactions. To protect customers' personal information, the bank uses data masking to replace the real account numbers and transaction details with fake but realistic looking data. So what we do is we replace the account numbers and transaction details with some fake data, but that is some kind of a realistic data. That is not the original data or that data which will be coming whenever we are doing a get query on our database which is present in the bank, but that is kind of a fake data which is giving us a realistic look, but that is not the original data. So this way the models can be trained effectively without risking the exposure of actual customer data. So consider if there is a ML model which we want to train. Now here we won't be providing the real data, right? We can't expose the real data to any machine learning models or any of the APIs. So what we do is we give some fake data which looks like a original data, and on basis of this data we train this particular model, so that whenever this particular model is implemented in real life scenario and whenever there is a original data which is coming to this particular model, it acts in a way in which we want. Now coming to some of the common data masking techniques. So first one is substitution. So replacing sensitive data with random but realistic looking values. For example, swapping real names with random names from a list. So what we have is, we have a names list which is having all the real names which is present in our database. So this is having all the real names which is present in our database. But I want to do some API testing for which I need the names, but I can't use the real names. So what I'll do is I'll create a random list which is having some random names. So we can use this random names for the API testing rather than the real names. So for example, a company's employee database containing social security number, that is SSN. To mask these, the company replaces the real SSN with randomly generated fake SSN. So consider if I have this particular SSN which is present in my database, and for testing I want a SSN. So what I'll do is I'll replace this real SSN with some fake SSN, and I'll substitute some of the values from this real SSN with some random values. So what I'll do here is, this is my real SSN which is present, and now I have to make some realistic, or you can say a fake SSN, so that I can use this for testing. So I'll substitute some of the values. Consider at 2 I am giving some random value 9. In 3 I am giving some random value 8. In 4 I am giving some random value 0. In 5 I am giving some random value 6. So in this way I'll substitute it with some random values and create a fake SSN which can be used for my testing. Now coming to the next one, that is shuffling. So rearranging the values within a column so that the data remains realistic but it's not linked to the original records. So in substitution, what we were doing is, if we had any value which is present in our database, consider that this was a SSN person number which is present in my database, I was substituting some of the values with some random values. So here I was substituting, consider 1 with any random value 9, 2 with any random value 8, 3 as it is, then 4 with any random value 1, 5 with any random value 3, then 1 with any random value 0 and 1. So in this way I was creating a random but original looking data. In shuffling, what it says is, consider if we have two columns, name and phone number. Now for a particular name Riti, we had a phone number 123, for Raj we had 456, and for Rahul we had 890. Now what we will do is we will shuffle the phone number in the column which is present, so that consider right now I have shuffled. So now Riti is having 456, Raj is having 890 and Rahul is having 123. So we have shuffled the data, and now this particular data we can use because 456 is linked with Raj, but right now I am using 456 for Riti. So now for Riti, 456 is a random value. So consider an example, a hospital has a list of patients with their birth dates. To protect privacy, the hospital shuffles the birth date among the patients. For instance, patient A birth date was 1/15/1990, which might be swapped with patient B's birth date, that is 7/22/1985. So what we had done is, if there are patient records which is present in my patient table, I am shuffling the birth date of some specific patient to protect the privacy, so that other people can't come ahead and access my real name, my real birth date and different things. So we are just shuffling the data between the records which is present in our table. Now coming to the third one, that is encryption. So encrypting a data so that it is unreadable without the decryption key. So we can encrypt the data so that it is unreadable without the decryption key. Now this can be used in the form of masking if the data does not needs to be human readable. So for example, a retail company encrypts credit card number in its database. A number like 411111 might be encrypted to something like this one, which is having some random characters, alphabets, special characters and much more things which can't be read without the decryption key. So once we have the decryption key, only then we can read this data. Now coming to the next one, that is nulling out. So replacing some sensitive data with null values or placeholders like X. This can remove the original data but may reduce the usefulness of the data set. So consider that I have my first name as Riti Kumari. So what I'll do is I'll use this Riti here, but I want to do some nulling out of the last name. So I'll provide KU and then X for the number of characters which is left. So example, an HR department wants to share employee records for analysis but needs to hide the salary information. They replace the salary field with the null values or placeholders like XXXXX. So in this way we can hide the salary information and can display the other details. Now coming to the next one, that is number variance. So altering numeric data by adding or subtracting a random value with a certain range. So whenever we want to alter the data by adding or subtracting some value of a given certain range, we use this number variance. For example, changing salary figures slightly to mask the data for the exact amounts. So for example, a finance department needs to protect the exact sales figure but still wants to share the data for the trend analysis. They slightly alter the figures by adding or subtracting a small random amount. For example, a sales figure of $10,000 might be changed to $10,020 or $9,980 so that we are able to analyze the trends, but we are able to mask the data as well. We are not showing the original or the real data. Now coming to the next technique, that is tokenization. So tokenization is a technique used to replace sensitive data with non-sensitive equivalents called as token. So what we do is, consider if we have a credit card. So we have some numbers 451633261241. Consider that this is a credit card number. So what we will do is we will give some tokens for some of the digits of this credit card number. So these tokens can be stored or processed without exposing the original sensitive data, while maintaining a mapping to the original values when needed. So whenever we want to maintain the mapping to the original values, like consider that these particular values are replaced by the token and we want to know that what are the original values for that particular token. So that is stored in a token vault. So there will be a token and then a particular value for that particular token. So example, imagine a database that stores customer credit card information. To protect the sensitive data, tokenization can be applied. Each original credit card number is replaced with a unique token. Consider TKNXYZ123. Now these tokens have no meaningful relationship to the actual credit card numbers. So these tokens doesn't have any meaningful relationship with the actual numbers of the credit card, but we provide this tokenization so that we can mask our sensitive sensitive information. So this was all about common database masking techniques. I hope you like this video. So if you like this video, please hit the like button. If you're someone who is new to my channel, can go ahead and watch out the tech content first. And if you find it useful, can go ahead and subscribe. Also, if you have not followed me on my social media handles, you can go ahead and follow. The links are in the description. Till then, take care, keep learning, keep growing, keep smiling. Bye all.